All right, let's take a look at the quiz. For the first question, we're asked to find the complement of the given angle. So recall that complementary angles are two positive angles such that the sum is 90 degrees. So when you add them together, you get a right angle basically. So for this one, we're given an angle that's 84 degrees. So basically you would take your 90 degrees, which is the sum of the two angles, and you would subtract away this angle that's given, which is 84 degrees, to get the missing angle, which is 6 degrees, right? 6 degrees plus 84 degrees gives you the 90 degrees. So this is the answer you're looking for, 6 degrees. All right, for question 2, we want to find the supplement of the given angle, and we are given 113 degrees. So for supplementary angles, they're two positive angles such that the sum is 180 degrees. So now what we can do is say 180 degrees minus 113 degrees. Well, if you key that into your calculator, you're going to get 67 degrees. So we want this 67 degrees here. So again, if you had a 67 degree angle and a 113 degree angle, they're two positive angles. And if you sum them together, you get 180 degrees. So that's our answer there. Okay, for question 3, we're asked to find the measure of each angle. And what you see here is that the total is going to be 90 degrees. This right here is going to be a right angle. And this guy right here, so this angle, let's just say this guy right here, we're given a measure of 20x minus 18 degrees. And then you have this angle right here, which is 6x plus 4 degrees. So I'm just going to add them together. So plus 6x plus 4 degrees. And I'm going to leave the degree symbol out of this for right now. We're just going to say that this sum, again, it's going to be 90 degrees, right? That's the sum right there. So this is equal to 90. So let's solve this really quickly. We'll figure out what x is, and then we'll go back and plug in. So 20x plus 6x is 26x. Then negative 18 plus 4 is going to be negative 14. So minus 14, we'll say this equals 90. Let's add 14 to both sides of the equation. Let's cancel this. We'll say 26x is equal to 90 plus 14 is 104. From here, let's divide both sides of the equation by 26. We'll cancel this and say x is equal to 104 divided by 26. That's going to be 4. And let me make this 6 a little bit cleaner here. Basically, this was 104 divided by 26, but the answer is x equals 4, but that's not what we're going to select. We have to go back and plug into these guys right here. So 20 times 4 would be 80, and 80 minus 18 is 62. So this guy right here is a 62 degree angle. And without even plugging in here, I know that this is 90 minus 62, or 28, right? So this guy would be a 28 degree angle, or you could plug in 6 times 4 is 24. 24 plus 4 is 28, okay? So this is going to be a 28 degree angle, and this one's a 62 degree angle. So this is what you want right here. So 28 degrees and then 62 degrees. Okay, for question 4, we want to find the measure of each angle. So just like the last example, only the difference is the sum here, this is going to be a straight angle, right? So it's 180 degrees. So you would take your 12x plus 13, again, leave the degree sign off, you don't need it for right now, plus your 10x plus 13, and we're going to, let me make this better, we're going to set this equal to 180. So 12x plus 10x is going to be 22x, 13 plus 13 is 26, so let's say plus 26, this equals 180. Let's subtract 26 away from each side. Let's cancel this and say that 22x is equal to 180 minus 26, that's going to be 154. And if I divide both sides of the equation by 22, we're going to find that x is 7. Right? So let me erase this so I have a little room to put this. I'll show this is canceling, and I'll just say x is 7. So now we're just going to plug in. So this one's a little bit easier to work with. So 10 times 7 is 70, and then 70 plus 13 is going to be 83. So I know that this angle right here is 83 degrees. And again, you could just say 180 minus 83, that's going to be 97. So I know that this guy right here is going to be 97 degrees. Or again, you could just plug in. So 12 times 7 would be 84. And then if you add 13, again, you get 97. So either way, you're going to have 97 degrees and 83 degrees. So coming down here, I want this one, the 97 degrees and then 83 degrees. All right, let's take a look at question 5. So we want to find the complementary angles with measures. We're given 7x minus 4 degrees, and we're given 3x plus 4 degrees. So again, if you have complementary angles, they're two positive angles with a sum of 90 degrees. So forget about the degree symbol. I'm not going to use that. I'm just going to say 7x minus 4 plus 3x plus 4 is equal to 90. And then this negative 4 and this plus 4, those are going to cancel. So 7x plus 3x is 10x, and this equals 90. Let's divide both sides of the equation by 10. This cancels. So you get x is equal to 90 over 10 is 9. So x here is going to be 9. So then you just plug back in. So 7 times 9 is 63. 63 minus 4 is going to be 59. So this first one is 59 degrees. And then the second one, 3 times 9 is 27. 27 plus 4 is 31. So this is 31 degrees. And again, if you sum those two positive angles, 59 degrees plus 31 degrees, you do get 90 degrees. So we'll select this one as the answer. Again, 59 degrees and 31 degrees. All right, let's take a look at the quiz. So for question 1, we're asked to find the sum. We are given 119 degrees, 3 minutes, 15 seconds. We're adding this to 12 degrees, 59 minutes, and 49 seconds. So once again, it helps to write out your relationship between degrees and minutes. So 1 degree is 60 minutes. And then the relationship between minutes and seconds. So we would say that 1 minute is equal to 60 seconds. Okay, so over here in the rightmost column, we add 15 plus 49. That's 64. So this means I have 64 seconds. Now what you want to do here, since this is 60 or larger, you want to break this up using these rules. You want to basically say that 64 seconds is 60 seconds plus 4 seconds. And then 60 seconds is 1 minute. So let's just say this is 1 minute plus 4 seconds. So let me keep the 4 seconds here in this column, and let me put this 1 minute up here in this column. The next thing we have is 1 minute plus 3 minutes plus 59 minutes. So 1 plus 3 is 4. 4 plus 59 is 63. So this is 63 minutes. But again, you think about this relationship here. So let's break this up and say that 63 minutes is 60 minutes plus 3 minutes, and 60 minutes is 1 degree. So I'm just going to say that this is 3 minutes down here, and I'm going to carry this 1 degree over here. So for this one, you have 1 degree plus 119 degrees plus 12 degrees. So 1 plus 119 is 120. 120 plus 12 is 132. So this is 132 degrees. Okay, so this would be my answer. 132 degrees, 3 minutes, 4 seconds. So this guy right here. Okay, for question 2, we're asked to find the difference. So here we'll have 13 degrees. We'll have 29 minutes and 17 seconds. Let me make this a little bit better here. And then minus, you have 8 degrees, you have 44 minutes, and you have 55 seconds. So I'm going to need to do a little bit of borrowing here. Again, 1 degree is equal to 60 minutes, and then 1 minute is equal to 60 seconds. So I don't have enough seconds up here, so what I want to do is borrow. I'm going to take 1 away from here, so I'll say this is 28 minutes. And with that minute that I took away, remember that's 60 seconds. So 60 plus 17 is going to be 77. So let's say this is 77 seconds now. And now I can do 77 minus 55. That's going to be 22. So this is 22 seconds. And this one is smaller than this one, so I'm going to borrow a degree. So let's say this is 12 degrees now. And with that degree I took away, 1 degree is 60 minutes. So 28 plus 60 is 88. So let's say that this is 88 minutes now. And 88 minus 44 is 44. So let's say this is 44 minutes. Then here I have 12 degrees minus 8 degrees. That's 4 degrees. So my answer here would be 4 degrees, 44 minutes, 22 seconds. So this guy right there. So for question 3, we are asked to find the complement of the given angle. So complementary angles are two angles that are positive angles, and the sum is 90 degrees. So for this one, I would just write 90 degrees, and I would subtract away the 81 degrees, 31 minutes, and 12 seconds. So again, you need to borrow here. And let me just write this out one more time. So 1 degree is equal to 60 minutes. And then you have that 1 minute is equal to 60 seconds. So I'm going to change 90 into 89 degrees. And with that degree I borrowed, I'm going to go ahead and write that as 60 minutes. And then I'm going to borrow from this and say this is 59 minutes. And with that minute that I borrowed, I'm going to say that this is 60 seconds. Okay, so now I can do my subtraction. 60 minus 12, that's going to be 48. So this is 48 seconds. Let me get rid of this. We don't need this anymore. Then 59 minutes minus 31 minutes. 59 minus 31, that's going to be 28. So this is 28 minutes. And then 89 degrees minus 81 degrees, that's going to be 8 degrees. So the complement of this angle is going to be 8 degrees, 28 minutes, 48 seconds. So this guy right there. All right, for question 4, we want to convert to degrees, minutes, and seconds. So let me write the relationship down here again. So we have 1 degree is equal to 60 minutes, and then we have 1 minute is equal to 60 seconds. So this right here, I have 312. what you want to do is take this 0.65 here and pull that away. So I'm going to put degrees here. I have a certain number of minutes and a certain number of seconds. That's what I'm looking for. So the 0.615, that's in terms of degrees right now. To put it in terms of minutes, well, there's 1 degree equaling 60 minutes. So I'm going to multiply by 60 minutes over 1 degree. Okay, so this is a unit fraction, and basically these two guys are equal, so this is like multiplying by 1, right? But it's a way to change the units. This is going to cancel with this. You always put the units you don't want in the denominator, and so what happens is 0.615 times 60, that's 36.9. So let me put 36.9. You're going to take that unit right there, so this is in terms of minutes. Now, I don't want the 0.9, I just want the 36, so just take the whole number, so this is 36 minutes, and then just take the 0.9, so 0.9, this is in terms of minutes right now, and you're going to do this again. So I want to convert this into seconds. So again, you want a unit fraction, put the unit you don't want in the denominator. So I'll go ahead and say this is 60 seconds over 1 minute. And again, the minutes I didn't want, so I'll put that in the denominator. So this cancels with this. And 0.9 times 60, that's going to be 54. So this is 54, and I keep those units, so seconds. So this would be 54 right there. And so we're ready for our answer. This is 312 degrees, 36 minutes, 54 seconds. So this guy right there. All right, let's take a look at question 5. So we want to convert to decimal degrees to the nearest thousandth. So again, we need a relationship where 1 degree is 60 minutes. And then also where we're going to say that 1 minute is 60 seconds. Okay, so let's start with this. I'm just going to write it out. So 14 degrees, 17 minutes, and then 18 seconds. The idea here is the 14 degrees, you can leave that alone, right? So I'm just going to put 14 degrees here. But I need to convert each of these, the minutes and the seconds, over to degrees. So you use these relationships here, and I'm actually going to need the other relationship here where we say that 1 degree is going to be 3,600 seconds. Okay, so this one right here, let me put plus. You have your 17 minutes, and I'm going to multiply this by, again, looking at this relationship here, I want to put 1 degree in the numerator and then 60 minutes in the denominator so that the minutes will cancel. So this is 17 over 60. So 17 over 60 degrees, then plus. For this relationship here, I'll say this is 18 seconds times, we'll say 1 degree over 3,600 seconds. So let's cancel this with this. And so you have 18 over 3,600. So let's put 18 over 3,600 and then degrees. Now, what I would do here to make this a little bit easier, I would get a common denominator. So I'd multiply this by 60 over 60. So let me actually move this down just a little bit and say this is times 60 over 60. Now 17 times 60 is 1,020. And then 1,020 plus 18, that's 1,038. So let me get rid of all this. And I'm just going to say this is 1,038 over 3,600 and then degrees. So key this into the calculator and you're going to get 0.288 and then a 3 that repeats forever. So let me put 0.288 and then I'm going to put this 3 with a bar on top and I'll put degrees. So let's put these two together and I'll say this is 14.283 repeating degrees. Now I want to round this to the nearest thousandth. So I'm looking at this guy right here, and the digit that follows is a 3. So because it's a 3, it falls in the category of 4 or less. So we will just leave this unchanged, and we will drop this off. So we'll say this is 14.288 degrees. And so looking up here, this is what we want. So the 14.288 degrees, again, this is an approximate answer. It's been rounded to the nearest thousandth. All right, let's take a look at our quiz. For the first question, we're asked to state if the two angles are coterminal angles. Remember, two angles are coterminal angles if they have the same initial side and the same terminal side, but their measures are going to differ by some multiple of 360 degrees. You can go 275 degrees minus a negative 25 degrees. Minus a negative is plus a positive. So this would be 275 degrees plus 25 degrees, which is 300 degrees. Now, is 300 degrees a multiple of 360 degrees? No. So that means these guys are not coterminal angles. All right, for question 2, we're again asked to state if the two angles are coterminal angles. So we have this 210 degrees, and I'm going to subtract away this negative 570 degrees. So we know that minus a negative is plus a positive. With this one, let's just show it. So we have 210 degrees plus 570 degrees. So what's that going to be equal to? Well, if I punch that into my calculator, I get 780 degrees. Now, is this a multiple of 360 degrees? No. 720 degrees would be a multiple of 360 degrees, but 780 degrees would not be. Now, if you're unsure about this, you can always divide on your calculator. You can just say 780 divided by 360, and you're looking for something that's not going to have a remainder, or in other words, you're looking for a non-zero integer result. Here, if you punch that in, you're going to get 2.16, where the 6 repeats forever. So we know that because this is not a multiple of 360 degrees, these two angles are not coterminal angles, so I'll select no. All right, for question 3, again, we're asked to state if the two angles are coterminal angles. So we have 305 degrees, and then we have negative 415 degrees. So let's go minus a negative 415 degrees. So this is 305 degrees plus 415 degrees. If we do that on our calculator, we get 720 degrees. Now for 720, it's 360 times 2, right? So this 720 degrees is a multiple of 360 degrees. Again, if you don't know that, you can just divide it on your calculator. 720 divided by 360 is 2. So because that's a non-zero integer, we can say these guys are coterminal angles. So your answer there is yes. All right, for question 4, we're asked to find a coterminal angle between 0 degrees and 360 degrees. We are given negative 222 degrees. For this, I would just add 360 degrees. And so that's going to give me 138 degrees. So that's what I'm looking for. This would be my answer. All right, for question 5, we want to find a coterminal angle between 0 degrees and 360 degrees. And we have negative 330 degrees. So again, I'm just going to add 360 degrees here. And that's going to give me 30 degrees. So that's what I'm looking for. So this guy right there. All right, let's take a look at the quiz. For the first question, we're asked to find the measure of each marked angle. So if we look at this guy, I'm trying to find the measure of this angle and this angle. So these two guys are what we call vertical angles. And so vertical angles have the same measure. So what I can do is actually set this expression here equal to this expression here, because we're told that the measure of this angle is the quantity 10x minus 33 degrees, and the measure of this angle is the quantity 6x plus 19 degrees. And again, those two angles, because they're vertical angles, would have equal measure. So I can just say that 10x minus 33, so this expression here, forget about the degree symbol, is equal to this guy right here, this 6x plus 19. Again, forget about the degree symbol. We're just going to solve this equation. So I'm going to subtract 6x away from each side. That would cancel. Let's add 33 to both sides. This would cancel. 10x minus 6x is 4x, and this equals 19 plus 33 is 52. Let's divide both sides of the equation by 4. And this will cancel, and you're going to get x is equal to 52 divided by 4 is 13. And let me just put that x is 13. Now, that's obviously not the answer. What you have to do is plug back in here and plug back in here. Now, you can plug into either one because they're vertical angles. The measure is going to be the same either way. So 10 times 13 would be 130, and then 130 minus 33, that's going to be 97. So the measure of this angle is 97 degrees. And again, the measure of this one is the same. It's 97 degrees. And you could plug in if you want. So 6 times 13, that's going to be 78. And then plus 19 is 97. So either way, you get 97 degrees by plugging in. Now, I just want to note this because there's a trap answer on this quiz question. We know that this guy right here, this angle right here, is a straight angle, right? So if I consider that this angle is 97 degrees, this angle right here would be 180 degrees. That's the entire angle here, the entire straight angle, minus this 97 degrees, which is going to be 83 degrees, right? So I can erase this and put this as 83 degrees, and this as 83 degrees. But the answer for this question, because it says each marked angle, I just want this one and this one, right? So it's going to be 97 degrees and then 97 degrees again. The 83 degrees is not going to come into play here. So we're going to come down here, and I'm going to circle this one as my answer. So 97 degrees and then 97 degrees again. Let's take a look at question 2 now. So we have that M and N are parallel lines. So this is line M and this is line N. So we want to find the measure of angle 1 and angle 2 given. We have the measure for angle 1 is going to be the quantity negative 8x plus 8 degrees. And then the measure of angle 2 is going to be the quantity negative 15x plus 57 degrees. Okay, so we know that this, I guess you would call it blue or green or turquoise, I'm not really sure. But this turquoise line, let's call it that, is going to be called a transversal, and it's intersecting these two parallel lines, the M and the N. Okay, so we know that this angle right here and this angle right here, which is alternate exterior angles, they're going to have the same measure. So if we say that the measure of angle 2 is this guy, this negative 15x plus 57, let me wrap this as a quantity and say degrees. Well, this guy right here plus this angle 1, which is the negative 8x plus 8, that quantity degrees, would form a straight angle. So this would be 180 degrees. So what you're going to do is just take this guy right here. Let me get rid of all this. And I'm going to add it to this guy right here. So negative 8x plus 8. And just set that sum equal to 180. And then we're going to solve. So let's go ahead and say negative 15x plus negative 8x. That's going to give me negative 23x. And then 57 plus 8, that's going to be 65. So let's go plus 65, and this equals 180. Let me subtract 65 away from each side of the equation. So that's going to cancel. And let me erase this. We don't need this anymore. I'm going to say that we have negative 23x is equal to 180 minus 65. It's going to be 115. Let me get rid of this. And actually, let me get rid of that. So I'm going to divide both sides of the equation by negative 23. And this would cancel. You get x is equal to, so positive over negative is negative, and 115 divided by 23 is 5. So I've got negative 5 as my value for x. So again, this is not the solution, okay? We're just going to plug that back in so we can figure out our angle measures. So for angle 1, again, it's negative 8 times this negative 5. I'm plugging that in for x, then plus 8, and it's this quantity degrees. So negative 8 times negative 5 is 40, and then 40 plus 8 is 48. So the measure of angle 1 is 48 degrees. So this is 48 degrees. So then the measure of this angle over here would be 180 degrees minus 48 degrees, which would be 132 degrees. And again, this and this, those are alternate exterior angles. So this would be 132 degrees as well. And if you want to fill this in, you could. This is 48 degrees. And then using some other properties, again, we're not asked for all this stuff, but these are vertical angles. So this is 48 degrees. These are vertical angles. So this is 132 degrees. These are vertical angles. So this is 132 degrees. These are vertical angles. So this is 48 degrees. So that's how you can get all 8 angles there if you want. Again, you could have also plugged in, so negative 15 times negative 5 is going to be 75, and then 75 plus 57 is also going to give you 132. So either way you do it, you're going to get 132 degrees. So we want 48 degrees for the measure of angle 1, and 132 degrees as the measure for angle 2. Let's see, so we want this one right here. So the measure of angle 1 is 48 degrees, and the measure of angle 2 is 132 degrees. All right, let's take a look at question 3 now. So we want to find the measure of angles 1, 2, and 3, given that the measure of angle 1 is this quantity 3x plus 18 degrees. The measure of angle 2 is the quantity 13x minus 42 degrees. And the measure of angle 3 is the quantity 7x minus 3 degrees. So we know that the sum of the measures of the angles of any triangle is 180 degrees. So I'm just going to say that 3x plus 18, forget about the degree symbol, then plus, we're going to take 13x minus 42, and then plus 7x minus 3. That's going to be equal to 180. Okay, let me slide this down a little bit so it fits. So you've got 3x plus 13x, that's 16x, plus 7x, that's going to be 23x. So this is 23x. You've got 18 minus 42, that's going to be negative 24. And then minus 3 would be negative 27. So let's set that equal to 180. Let's add 27 to both sides of the equation. This cancels. You get 23x is equal to 180 plus 27, that's going to give you 207. Let me divide both sides of the equation by 23. Let's cancel this. We'll say x is equal to 207 divided by 23 is 9. Okay, so let's just plug in. For angle 1, you've got 3x plus 18, that quantity degrees. 3 times 9 is 27. 27 plus 18, that's going to be 45. So for angle number 1, that's 45 degrees. Then for angle number 2, you've got the quantity 13x minus 42 degrees. So 13 times 9 is 117. Then minus 42, that's going to be 75. So for angle 2, the measure is 75 degrees. And then for angle 3, you can plug in 7 times 9 is 63. 63 minus 3 is 60. So this is 60 degrees. Or you could have said that 45 degrees plus 75 degrees is 120 degrees. And again, the sum of all the angle measures is going to be 180 degrees. So you could have done 180 degrees minus 120 degrees to get your 60 degrees there. So either way, the measure for angle 1 is 45 degrees. The measure for angle 2 is 75 degrees. And the measure for angle 3 is 60 degrees. So I'm going to want to select this answer right here. So again, the measure of angle 1 is 45 degrees, the measure of angle 2 is 75 degrees, and the measure of angle 3 is 60 degrees. All right, let's take a look at question 4. So given that triangle ABC and triangle EFD are similar, find the measure of each angle given that angle A, the measure has this quantity 10x minus 43 degrees. Angle D, the measure is this quantity 3x minus 7 degrees. And for angle B, the measure is this quantity 2x plus 5 degrees. All right, so remember with similar triangles, corresponding angles have equal measure. Okay, so looking at this guy, you can either go based on a statement. So if I have A first here and E first here, well, that means angle A corresponds to angle E. You can also see the matching arcs here, right? You have 3 and you have 3. Then you have B and then you have F, right? So angle B corresponds to angle F. Again, double arc here and double arc here. And then you lastly have angle C that's going to correspond to angle D. So a single arc here and a single arc here. Okay, so now that we know that, let's try to fill in what we can. So for angle A, that's this one, I have something. For angle B, I have something. And then I have something for angle D. But remember, angle D corresponds to angle C. So I have a measure for angle A, B, and C. And remember, the sum of all the measures of the angles in a triangle is going to be 180 degrees. So I can just sum these guys. So 10x minus 43. So that's going to be for the angle A. And then plus, for angle C, I'm using the one from angle D because, again, they're corresponding angles and they have the same measure. So this is 3x minus 7. Then plus for angle B, I'm going to say this is 2x plus 5. So this guy right here, let me come to a fresh page. I'll say this is equal to 180. And let's just solve this. So 10x plus 3x is 13x. Plus 2x would be 15x. Negative 43 minus 7 is negative 50. And then negative 50 plus 5 is negative 45. So this equals 180. What we'll do here is add 45 to both sides of the equation. This would cancel. You get 15x is equal to, this would be 225. Let's divide both sides of the equation by 15. This would cancel. And you're going to get that x is equal to 225 divided by 15 is 15. All right, so now that we know x is 15, it's just a matter of plugging things in. So 10 times 15 is 150. 150 minus 43, that's going to be 107. So the measure for angle A and also for angle E, because they're corresponding angles, that's going to be 107 degrees. And you could write it in here if you wanted to, but I don't think it's going to be able to fit and I'd have to arrow to things. So I'm just going to write it off to the side. So next, let's look at angles C and D. So let me put C and D here. What's that equal to? So 3 times, again, x was 15. 3 times 15 is 45. 45 minus 7, that's going to be 38. So this is 38 degrees. And then lastly, you're going to have B and F. So B and F. And you can plug in if you want, or you can use the angle sum property of a triangle, whatever you want to do. I think it's probably easier just to plug in. So 2 times 15 is 30, and 30 plus 5 is 35. So this is 35 degrees. Or again, you could have said that 107 degrees plus 38 degrees, that's 145 degrees. And if you subtract 180 degrees minus 145 degrees, you would get that 35 degrees. Okay, so looking through the answers, I'm going to want this first one right here. So angles A and E are 107 degrees. Angles C and D are 38 degrees. And then finally, angles F and B are 35 degrees. All right, for question 5, we are told to find the lengths of the unknown sides. We have that triangles ACB, so ACB, and DFE, so DFE are similar. Now, with this guy here, it's a little bit difficult because things are flipped around. You can see that you have these arcs that you can match up if you want to redraw the triangle, but I think it's easier here just to use a similarity statement. So if you've never taken geometry and you're just taking trigonometry on your own, then basically you could set this up like this and say triangle ACB, okay, is similar to this triangle DFE. And when we write it in this manner, we can see the corresponding sides. So I can say these first 2 letters here, this side AC, so this is the side AC, it's going to correspond to this side here, the first 2 letters, the DF. Okay, so the DF. And you can see that this one starts with 1 arc and goes to the 2 arc. Starts with 1 arc, goes to the 2 arc. So it's always going to work out that way, okay, when you use this similarity statement. So the other sides, let me actually write this. I'm going to set up my ratios and we'll talk about what we're doing in a moment. So let's go, side AC is going to correspond to side DF. I'm going to say this is equal to, you're going to have side CB, so the final 2 letters, that's going to correspond to side FE, so side FE. And again, you can see this. So this is side CB, and then this is side FE. So you can see that starting here, you're at 2 arcs going to 3, 2 arcs going to 3. Okay, let me put equals. For the last one, you can say side AB. So let's call it that. So side AB. And that is going to correspond to this side DE. So this side DE. So let's find this. So AB, so single arc to triple, and then DE, so single arc to triple. Again, if you want to match it up with the arcs, that's up to you. In some cases, when you're in your book, they might not give you matching arcs, right? They might give you 2 triangles and a similarity statement, just depending on what book you're in. Okay, so once we have this set up, I want you to think about, with similar triangles, we know the corresponding angles must be equal, but also the corresponding sides must be proportional. So this just means that the ratios of their corresponding sides must be equal. So that's what I did here. I just set up a little proportion. We are saying that basically the ratio where we have the length of the side AC, okay, to the length of the side DF is the same as the length of the side CB to the length of the side FE, which is the same as the length of the side AB to the length of the side DE. Okay, now let's fill in the information we're given. So side AB has length 24. So I'm going to put it right here, and I'm going to erase it from here and put that right there. And then we have side AC, so that's right here, has length 16. So let me erase that here and put 16 in there. And then side CB, that's going to have length 32. So let me put 32 there. And let me erase this and put 32 there. And then side FE, so that's FE like this, that's going to have length 50. Now, I don't want this to get confused with the other guy, so let me do this in a different color. So that's for this guy right here. So let me erase this and put this as 50. Now, I would recommend simplifying this. With 32 and 50, there's a common factor of 2. So 32 divided by 2 is 16. 50 divided by 2 is 25. Okay, that's just going to make it a little bit easier. Let me grab this real quick. All right, so we're going to solve one of these at a time. You're going to take this guy right here, set it equal to this guy. Then you'll say this guy is equal to this guy. So you have 16 over DF, that's the length of that side, is equal to 16 over 25. So again, if you have the same numerator in each case, well, then the denominators have to be equal, right? You can cross multiply if you want, but I'm just going to tell you DF here would have to be 25. We would say DF, that's the length of that side, that's going to be 25. So this right here, this is 25. So now what you're going to do is take the other part. So let me go 24 over the length of that side DE is equal to 16 over 25. So now we're not so lucky. We have to do some math. So let's cross multiply. So we're going to say that 16 times DE, which is the length of that side, is equal to 24 times 25. So that's going to be 600. Divide both sides by 16. This would cancel. So the length of the side DE is going to be 600 divided by 16. Let's say that's 37.5 as a decimal. So for side DE, the length is going to be 37.5. So let's put 37.5 in there. Okay, so coming down here, I'm looking for side DF is going to have a length of 25, and then side DE is going to have a length of 37.5. So this guy right there. All right, let's take a look at the quiz. For question 1, we're asked to use the given point on the terminal side of angle theta to find the value of the trigonometric function indicated. So we want to find the cosine of theta, which recall is going to be x over r, given the fact that we have an x value of 2. So we have an x value of 2, and we have a y value of negative 2 times the square root of 3. Okay, so what we're going to do is just plug in. For x, we know we can plug in a 2. And then for r, this is going to be the square root of x squared. So 2 is x. So 2 squared is 4. Plus you have your y squared. So you have a negative 2 squared, which is 4, times the square root of 3 being squared is 3. So 4 times 3 is 12. And so 4 plus 12 is going to be 16. And the square root of 16 is 4. So r is 4 here. So essentially what you would say is that the cosine of theta is 2 over 4, which is really just a half if you simplify it. So we want this guy right here. So cosine of theta is equal to a half. Okay, for question 2, again, we want to use the given point on the terminal side of angle theta to find the value of the trigonometric function indicated. So now we want to find the secant. So the secant of theta, which is going to be the reciprocal of the cosine of theta. So this is r over x now. And this is given the fact that we know that the x value is 5, so x is 5, and the y value is going to be negative 20. So again, plug in what you know. So I know x is 5, so let's just get rid of this and put a 5 here. And then what I can say is that I need my r. So r is equal to the square root of x squared. So 5 is x. If I square that, I get 25. Then plus y squared. So negative 20 is my y. If I square negative 20, I get 400. So essentially, this would be the square root of 425. So we would have to think about how to simplify that. And so I can actually break this up into 25 times 17. 25 is a perfect square. So let's say this is 5 times the square root of 17. Okay, so let me get rid of all this and just say that r is 5 times the square root of 17. Now, you can see that this 5 is going to cancel with this 5. And so the secant of theta is just going to be the square root of 17. So I'm looking for this answer right here, right? The secant of theta is the square root of 17. Okay, let's look at question 3 now. So use the given point on the terminal side of angle theta to find the value of the trigonometric function indicated. We want to find the cotangent of theta. So the cotangent of theta, which again is going to be the reciprocal of the tangent of theta. So the tangent of theta is y over x. So the cotangent of theta is the reciprocal, so it's x over y. So this is x over y. Now, we are given an x value, which is going to be the negative of the square root of 19. We are given a y value, which is negative 9. So for x, let's get rid of this, and let's put negative square root of 19. For y, let's get rid of this, and let's put negative 9. So those negatives would cancel, and you'd be left with the cotangent of theta being equal to the square root of 19 over 9. So I want this guy right here. The cotangent of theta is equal to the square root of 19 over 9. Okay, let's take a look at question 4. So again, we want to use the given point on the terminal side of angle theta to find the value of the trigonometric function indicated. So we want to find the tangent, so the tangent of theta, which again is y over x. This is given the fact that our x value is negative 4. Let me make that better. And then the y value is going to be negative 3. Okay, so just plug in. So for y, you have negative 3. And then for x, you have negative 4. So we know that negative over negative is positive. So we can just say the tangent of theta is going to be equal to 3/4. So coming down here, the tangent of theta is 3/4. All right, for question 5, now we want to find sine of theta if its terminal side is defined by the given ray. So we have negative 2x plus 3y equals 0. So that's a line passing through the origin. But we're saying here specifically that x is greater than or equal to 0. So for this type of problem, you want to pick something that's not 0 for x. So you don't want 0, 0 as your point. Pick something other than that to where you're not going to violate this guy. So you want to say x is something that's greater than 0. To make it work out, I'm just going to pick x is equal to 3. So I'm going to say this is negative 2 times, I'm going to have positive 3 plus 3y is equal to 0. So here I'm just saying x is equal to 3. You could have picked, again, anything that was greater than 0. So it could be 3 or 10 or 1 trillion, whatever you want to do. I'm just picking 3 because I know it's going to work out. Okay, so let's move this down here a little bit. So negative 2 times 3 is negative 6. So this is negative 6 plus 3y is equal to 0. Add 6 to both sides, and you would have 3y is equal to 6. Divide both sides by 3, you'd have y is equal to 2. So a point on the terminal side is going to be an x value of 3 and a y value of 2, or the ordered pair 3, 2. Let me get rid of this. And however you want to write that, if you want to put it as an ordered pair and say it's going to be 3, 2, or if you want to say x is 3 and y is 2, whatever you want to do. The main thing here is you're going to have to find r. So r is the square root of x squared. So x is 3, so 3 squared is 9. Plus 2 squared. 2 squared is 4. So 9 plus 4 is 13. So r is the square root of 13. Okay, so we know that the sine of theta is going to be y, which is 2, over r, which is the square root of 13. We want to rationalize the denominator, so multiply this by the square root of 13 over the square root of 13. So this gives me a final answer for the sine of theta of 2 times the square root of 13 over 13. Okay, so looking for my answer, it's right here. So the sine of theta equals 2 times the square root of 13 over 13. All right, let's take a look at the quiz. For the first question, we're asked to find the cotangent of theta, given that the cosine of theta is equal to negative 21 over 29, and the sine of theta is less than 0, or you could say it's negative. So first and foremost, we have a negative cosine value and a negative sine value. So cosine is negative in quadrants 2 and 3. Sine is negative in quadrants 3 and 4. So this guy, our angle theta, is going to be in quadrant 3. So let's say that theta is in quadrant 3. And let me make this a little bit better there. So let me write out what we have. So the cosine of theta, we know is x over r. And right now we're given negative 21 over 29. And what we want to say here is that in quadrant 3, the x values are negative and the y values are negative. I know that r is always positive, so I'm going to go ahead and say that x is negative 21 and r is positive 29. So I just need to figure out what is y. I know it's negative, but I don't know what value it is. So to figure that out, we're going to plug into our little formula. So we'll say that r is equal to the square root of x squared plus y squared. Plug in what you know. So r is 29. So this is 29. And then x is negative 21. So negative 21 squared, that's going to be 441. So let's put 441 in there. And then you could just square both sides. So square both sides like this. And so 29 squared, that's 841. And this equals, this guy, if I square it, you'd have y squared plus 441. If you subtract 441 away from each side of the equation, this is going to cancel. So you're going to end up with y squared is equal to 841 minus 441 is 400. Let me erase all this. So if you have y squared equals 400 by the square root property, y is equal to plus or minus the square root of 400, and the square root of 400 is 20. Now, again, we are in quadrant 3, so I want to pick negative 20 for my y value, because again, the y values in quadrant 3 are negative. So coming back up here, again, I wanted to find the cotangent of theta. And so I need the x value over the y value. So the x value is negative 21. The y value is negative 20. And so this would be 21 over 20. And so looking through my answers, I want this one. The cotangent of theta is going to be equal to 21 over 20. All right, let's take a look at question 2. So here we want to find the cosine of theta, given the fact that the tangent of theta, so the tangent of theta, let me write this out. This is y over x, and this is the square root of 3 over 3. Okay, so this guy's positive. Sine of theta is going to be negative here, right? It's less than 0. And this is only going to occur in quadrant 3, right? Because tangent and cotangent are positive in quadrant 3, and your sine is negative in quadrant 3. So that's the overlap. Okay, so thinking about this guy here, I know that if I'm in quadrant 3, let me write this out so nobody's lost. So theta is in quadrant number 3. If I'm in quadrant 3, then the x and the y values are both negative, okay? So that means that the y here is going to be the negative of the square root of 3, and the x here is negative 3, right? Again, if you plug that in, a negative over a negative is a positive, so that's how you get this. So for the cosine of theta, we are going to need the r value. Let me write this down here. I don't think I have enough room, so let me put a comma and just say r is equal to the square root of. You have x squared, so negative 3 squared is 9, and then plus the negative of the square root of 3 squared. The negative is going to go away. Square root of 3 squared is 3. So 9 plus 3 is 12. And 12, you could factor that into 4 times 3. 4 is a perfect square. Square root of 4 is 2. So this is 2 times square root of 3. So 2 times square root of 3. Okay. If we want to find the cosine of theta, well, that's going to be, let me write this over here. The cosine of theta is x, which is negative 3, over r, which is 2 times square root of 3. Now, you would need to rationalize the denominator. So let me multiply by the square root of 3 over the square root of 3. And what's going to happen is square root of 3 times square root of 3 is 3. And then what you can do is cancel this 3 with this 3. So this is the negative of the square root of 3 over 2. So let me write this as the negative of the square root of 3 over 2. And I'm going to look for that answer. So it's this guy right here. So the cosine of theta is equal to the negative of the square root of 3 over 2. Okay, let's take a look at question 3 now. So we want to find the secant of theta, given that the cotangent of theta is 24 over 7, and the cosine of theta is negative, or you could say less than 0. So for the cotangent of theta, this is 24 over 7. So this is positive, right? And let me actually write out that this is x over y, so that's more clear, and this is 24 over 7. We know also that the cosine of theta is negative. Now, if the cosine of theta is negative, that means I'm in either quadrant 2 or quadrant 3. But in quadrant 2, cotangent is negative. And here it's positive, so we must be in quadrant 3, right? So cotangent is positive in quadrant 3, and cosine is negative in quadrant 3. So we're going to say that theta is in quadrant 3. Okay, and then we're good to go. So this tells me, since I'm in quadrant 3, that my x values are negative, so this would be a negative 24. And my y values are negative, so this would be a negative 7. Now I need my r value, and basically, again, this is the square root of x squared, so negative 24 squared. That's going to be 576. Then plus y squared, so negative 7 squared is 49. If you do 576 plus 49, that's 625. So this is 625. If you hit the square root key on your calculator, you're going to get 25. Okay, so we have our x, our y, and our r. And for the secant of theta, let me write this over here, the secant of theta, this is equal to the r value over the x value. So the r value is 25, and the x value is negative 24. So we'll just say that the secant of theta is the negative of 25 over 24. So it's going to be this guy up here, right? So the secant of theta is equal to the negative of 25 over 24. All right, let's take a look at question 4. So we want to find the sine of theta, given that the tangent of theta is equal to 8 over 15, and the sine of theta is greater than 0 or positive. So this tells me I'm in quadrant 1, right? So sine is going to be positive in quadrants 1 and 2, and tangent is positive in quadrants 1 and 3, okay? So I know that theta is in quadrant 1. So all the x values and y values are positive. And so what I would do here is if I had the tangent of theta, again, this is y over x, well, this is equal to 8 over 15. Well, that's telling me that x is going to be 15 and y is going to be 8. Okay, so it's pretty simple. Now we need the r value here. So that's equal to the square root of x squared plus y squared. So 15 squared is 225. And then plus 8 squared, that's going to be 64. So 225 plus 64 is 289. And then the square root of 289 is 17. So let me erase this and first put this as the square root of 289. Again, if you did this on your calculator, you would get 17. And so now if you want the sine of theta, it's going to be y over r, which in this case, the y is 8 and the r is 17. So it's just going to be 8 over 17. So looking through the choices, I want this one right here. The sine of theta is equal to 8 over 17. All right, for question 5, we want to find the cosecant of theta. And we are told that the secant of theta, which is the reciprocal of the cosine of theta, this is r over x. And here this is the negative of the square root of 10 over 3. So secant and cosine are negative in quadrants 2 and 3. Now we're told that sine is positive. Sine is positive in quadrant 1 and 2. So we have to be in quadrant 2. So we'll say that theta is in quadrant number 2. Maybe I'll make that a little bit cleaner there. Now, if we're in quadrant 2, the x values are negative and the y values are positive. So let's say that your x value here is negative 3 and your r value here is the square root of 10. Okay, so just looking at this, I know that x is negative in this quadrant, so I'm taking this as a negative 3, and r is always positive, so that's going to be square root of 10. For the y value, again, you could just plug in. I know it's going to be positive because we are in quadrant 2, but I'll just say that r is equal to the square root of x squared plus y squared, and then basically for r, it's the square root of 10, so square root of 10. And then for x, it's negative 3, so if I square that, I get 9. And if I square both sides, let me show this so nobody's lost. I'm going to get 10 is equal to y squared plus 9. Okay, let me get rid of this so we have enough room. And then from there, you would subtract 9 away from each side, so you get y squared is equal to 1. If I use my square root property, then you get y is equal to plus or minus the square root of 1, which is 1. Okay, so again, because we're in quadrant 2, we're going to pick a y value of positive 1. And so if we're trying to find the cosecant of theta, that's going to be r over y, right? It's the reciprocal of sine. So in this particular case, your r is the square root of 10, and your y is 1. So this is just the square root of 10. So looking through my choices, I want to say that cosecant of theta is the square root of 10. All right, let's take a look at the quiz. For the first question, we're asked to use identities to find the value of each expression. We want to find the tangent of theta and the cotangent of theta, given that the sine of theta is 1/4 and the tangent of theta is greater than 0. So sine is positive in quadrants 1 and 2. Tangent is positive in quadrants 1 and 3. So we know that theta is in quadrant 1. Now we want to find the tangent of theta and we want to find the cotangent of theta. Now those guys are reciprocals. So you can just find one of them and then flip it and get the other. So which one do we want to find? Well, we could use the identity that says 1 plus your cotangent squared theta is equal to your cosecant squared theta. Now, we know that cosecant and sine are reciprocals. So if sine of theta is 1/4, that means cosecant of theta is 4/1 or just 4. Now, we would want to square that, so cosecant squared of theta would be 16. Okay, so let me put this as 16. And in case anybody is lost, I'm just going to put that cosecant of theta is equal to 4. Okay, so I just took 4 and I squared it and I put it there. So now you would subtract 1 away from each side. So I'm going to get rid of that from over here. And I'm going to subtract 1 over here. So this is just 15. So the cotangent squared theta is equal to 15. Again, using the square root property, you just take the square root of each side and say this is cotangent of theta is equal to, don't forget the plus or minus over here, the square root of 15. Now, when we think about this guy again, we're in quadrant 1, so everything is going to be positive. Okay, so I just want the principal square root of 15. So the cotangent of theta would be the square root of 15, and then for the tangent of theta, I'm just going to flip this guy so it's 1 over the square root of 15. You would then rationalize the denominator, so I'm going to multiply this by the square root of 15 over the square root of 15. So this will be the square root of 15 over 15. So the square root of 15 over 15. So I'm looking for this answer right here. So the tangent of theta is the square root of 15 over 15, and the cotangent of theta is the square root of 15. All right, for question 2, again, we're asked to use identities to find the value of each expression. We want to find the cosine of theta and the sine of theta, given that the cotangent of theta is 5/3 and the sine of theta is greater than 0. So the cotangent of theta being positive and the sine of theta being positive, that's going to occur in quadrant 1. Sine is positive in quadrants 1 and 2. Cotangent is positive in quadrants 1 and 3. So I'm going to say that theta is in quadrant 1. Now we're given cotangent, and that's 5/3. So let's start off by figuring out the sine of theta. And to do that, I'm going to use my identity, which is 1 plus, let's say the cotangent squared theta is equal to cosecant squared theta. And remember, the cosecant is the reciprocal of sine. So we'll figure out what cosecant of theta is. We'll flip it. We'll have the sine of theta. Okay, so let's plug in. We know that cotangent of theta is 5/3, but we want cotangent squared of theta. So we want 5/3 squared, which would be 25/9. I'm going to switch this and say this is 9 over 9. So 9 plus 25, that's going to be 34. So let's say that this is 34 over 9. So by the square root property, you could say that the cosecant of theta is equal to the principal square root, because we're in quadrant 1, of 34 over 9. Again, normally you do plus or minus, but since we're in quadrant 1, we know this is positive. And so this would be the square root of 34 over the square root of 9, which is 3. So the square root of 34 over 3. Again, if you want your sine of theta, you're going to flip this, so it's 3 over the square root of 34. Now let's hold that for a moment. We'll rationalize the denominator in a moment. We know to get cosine of theta, we want cosine squared theta is equal to 1 minus sine squared theta. And all I did was I took sine squared theta plus cosine squared theta equals 1, and I just rearranged it so we could solve for cosine squared theta. That's all I did. So I'm going to plug in here for sine squared theta. So I have 3 over square root of 34 for the sine of theta. So I'm going to plug in 3 over the square root of 34, and I'm going to square that. And then what I'll have is cosine squared theta is equal to 1 minus, if I square 3, I get 9. If I square the square root of 34, I get 34. So let me write this as 34 over 34. So 34 minus 9, that's going to be 25. So this would be 25 over 34. So let me get rid of this. I'm trying to keep this on one sheet. So from the square root property, I could say that the cosine of theta is equal to, again, normally it's plus or minus, but we're in quadrant 1. So let's just say the principal square root of 25 over 34. So this would be the square root of 25, which is 5, over the square root of 34. So 5 over the square root of 34. So I'm going to multiply by the square root of 34 over the square root of 34. So this becomes 5 times square root of 34 over 34. So 5 times square root of 34 over 34. And then down here, I'm going to do the same thing. So multiply by the square root of 34 over the square root of 34. So this is 3 times square root of 34 over 34. So 3 times square root of 34. Let me put that up here. Over your 34. Okay, so looking for my answer, let me get rid of this. We don't need this anymore. I'm looking for this one right here, which says that cosine of theta is equal to 5 times square root of 34 over 34. And sine of theta is equal to 3 times square root of 34 over 34. All right, for question 3, we're going to use identities to find the value of each expression. We want to find cosecant of theta and sine of theta, given that the cotangent of theta is negative 2/5 and the secant of theta is less than 0. So we have a cotangent value that is negative. That's going to occur in quadrants 2 and 4. We have a secant value, which is negative. Remember, secant is the reciprocal of cosine. So we're going to say that that's going to be negative in quadrants 2 and 3. So the overlap here is going to be in quadrant 2. So let's say that theta is in quadrant 2. So looking at what we have here, we're trying to find the cosecant of theta and the sine of theta. Now we're given cotangent of theta. So I can plug into my Pythagorean identity that says that 1 plus the cotangent squared theta is equal to the cosecant squared theta. And so for this one, I'm just going to plug in for cotangent of theta, negative 2/5, and then I need to square it, okay? Because this is cotangent squared theta. So let me get rid of this and put negative 2/5 like this. And I'm going to square that, so that would give me 4 over 25. So you'd basically have 1 plus 4 over 25. And if you get a common denominator here, you just say this is 25 over 25. So this is going to be 29 over 25. So 29 over 25. So if I want cosecant of theta, what I would do is say I have plus or minus the square root of this guy right here, which is 29 over 25. Now I'm in quadrant 2. Cosecant is the reciprocal of sine, and it's positive in quadrant 2. So I'm going to take the principal square root there. And this would just break up into the square root of 29 over 5. So this is the square root of 29 over 5. Okay, so now what I want to do is figure out what is the sine of theta. Well, remember, the cosecant of theta and the sine of theta are reciprocals. So the sine of theta is equal to 5 over the square root of 29. And of course, we would rationalize the denominator. So times the square root of 29 over the square root of 29. So this is 5 times square root of 29 over 29. So 5 times square root of 29. This is over 29. So looking through my answers, I want this one right here. So the cosecant of theta is square root of 29 over 5. And the sine of theta is 5 times square root of 29 over 29. Okay, let's take a look at question 4. So we want to use identities to find the value of each expression. We want to find secant of theta and cosine of theta, given that the cotangent of theta equals 2 and the cosine of theta is less than 0. So if the cotangent is positive, that can only occur in quadrants 1 and 3, and the cosine is negative, which can only occur in quadrants 2 and 3, well, I know I'm in quadrant 3. So let's say that theta is in quadrant 3. So now we want to find the secant of theta and the cosine of theta. So those are reciprocals. So what I'm going to do is plug into my Pythagorean identity that says that the tangent squared theta plus 1 is equal to your secant squared theta. Now, I have my tangent of theta because if I know cotangent of theta is 2, well, I can flip that and get tangent of theta as 1/2. So let me write that over to the side here. I don't have much room. Let me put it over here. So tangent of theta is the reciprocal of cotangent of theta, so it's just 1/2. So you're going to plug in here, but remember, you have to square this. Common mistake is to forget that. So you'd have 1/2 here and just square that. So you're going to have 1/4 plus 1, let's just say that's 4 over 4, is equal to secant squared theta. And so 1 plus 4 is 5, so this is 5/4. So let's just write this as secant squared theta is equal to 5/4. So from the square root property, you would say the secant of theta is equal to plus or minus the square root of 5/4. So in this case, we're in quadrant 3. So secant and cosine are negative. So I want the negative square root. And so this would be the negative of the square root of 5 over the square root of 4 is 2. So the negative of the square root of 5 over 2. Let me get rid of all of this. If you want your cosine of theta, then just take the reciprocal of this. So this is the negative of 2 over the square root of 5. Let's go ahead and rationalize the denominator. So times the square root of 5 over the square root of 5. So this would be the negative, let me slide this down just a little bit, of 2 times the square root of 5 over 5. So I'm looking for this guy right here. So the secant of theta is equal to the negative of the square root of 5 over 2. And the cosine of theta is equal to the negative of 2 times square root of 5 over 5. All right, let's take a look at question 5. So again, we want to use identities to find the value of each expression. We want to find cosine of theta and sine of theta, given that the secant of theta is -5 and the sine of theta is less than 0. For secant and cosine, they are negative in quadrants 2 and 3. For sine, it's negative in quadrants 3 and 4. So that tells me I'm going to be in quadrant 3. So theta is in quadrant 3. Okay, so the next part is we want to find cosine of theta and sine of theta. So if I'm given the secant of theta, the reciprocal of that is the cosine of theta. So in other words, if the secant of theta is -5, well then the cosine of theta is going to be -1/5. Now for the sine of theta, again, you can just plug in to the Pythagorean identity. You have sine squared theta plus cosine squared theta is 1. Well here, let me solve for sine squared theta. So sine squared theta is equal to 1 minus your cosine squared theta. Now cosine of theta is -1/5. Again, you have to square this. So I'm going to say this is -1/5 being squared. Let's make that 5 better. So this would be 1/25. Okay, so this is 1/25. Now, I would take this 1 here and write it as 25/25. So you have a common denominator. 25 minus 1 is 24. So this is 24/25. So from the square root property, we would say sine of theta is equal to plus or minus the square root of 24/25. We are in quadrant 3, so sine is negative. So let's use the negative square root. And so this is going to break up into the square root of 24. So the square root of 24 over, for the square root of 25, that's 5. Now the square root of 24 can be simplified. So let's do that real quick. I'm going to put this negative out in front here. The square root of 24 is the square root of 4 times the square root of 6, and the square root of 4 is 2. So let's say that this is 2 times the square root of 6. So looking for my answer, I want sine of theta to be equal to the negative of 2 times square root of 6 over 5, and cosine of theta to be equal to -1/5. So looking through my answers, I want this guy right here. So the cosine of theta is equal to -1/5, and the sine of theta is equal to the negative of 2 times square root of 6 over 5. All right, let's take a look at the section quiz. For the first question, we're asked to find the supplementary angles with measures. We're going to have the quantity 10x minus 28 degrees, and we're going to have the quantity 3x plus 13 degrees. Now, supplementary angles are going to sum to 180 degrees. In other words, it would form a straight angle. So all you have to do is take the 10x minus 28, forget about the degree symbol for right now, then add that to the 3x plus 13. Again, don't worry about the degree symbol for right now. We're going to set that equal to 180 for 180 degrees. And so 10x plus 3x would be 13x. Negative 28 plus 13, that's going to be -15. So this equals 180. What we'll do is add 15 to both sides of the equation. This would cancel. You get 13x is equal to 180 plus 15 is 195. Let's divide both sides of the equation by 13. This would cancel, and you're going to end up with x is equal to 195 divided by 13. That's going to be 15. Okay, so we know x equals 15, but that's not the answer. We have to go and plug into each one. And so for the first one, you add 10 times x. Now x is 15, so plug in a 15. So 10 times 15 minus 28. So this quantity degrees. So 10 times 15 is 150, and then 150 minus 28, that's going to be 122. So this is 122 degrees, okay? Now for the other one, you can plug in a 15. So 3 times 15 is 45. And then 45 plus 13, that's going to be 58 for 58 degrees. So you could do it that way, or you could again realize that supplementary angles have a sum of 180 degrees. So you could say 180 degrees minus 122 degrees would give me my 58 degrees. So whatever you want to do in that situation, this is going to be our answer here. So 122 degrees and then 58 degrees. Okay, for question 2, we are asked to find the complement of the given angle, and the angle that's given is 7 degrees. So complementary angles are going to be angles that are going to sum to 90 degrees. So for this particular case, you have 7 degrees, so you can just say 90 degrees minus 7 degrees, that's going to be 83 degrees. So the complement of this angle, which is 7 degrees, is going to be 83 degrees. All right, for question 3, we want to find the sum, and I'm just going to do this vertically. We have 39 degrees. we have 5 minutes, and then we have 19 seconds. We're going to add this to, we have 22 degrees, 15 minutes, and 18 seconds. Okay, so what we're going to do is add in the rightmost column here with the seconds. You have 19 seconds plus 18 seconds. That's going to give us 37 seconds. Now, this is not 60 or larger, so we don't need to carry or do anything like that. We just go into the next column to the left. Here we have 5 minutes plus 15 minutes. That's going to give me 20 minutes. Again, it's not 60 or larger, so you just move to the left. Now we have 39 degrees plus 22 degrees, and that's going to give me 61 degrees. So the sum here is 61 degrees, 20 minutes, 37 seconds. So we want this answer right here. All right, for question 4, we are asked to convert to degrees, minutes, and seconds. So we have 55.91 degrees, and we would like to end up with something degrees, something minutes, and something seconds. So how do we do that? Well, first off, just take the number that occurs to the left of the decimal point, so this 55, just put that right here. So you have 55 degrees. Now, for the minutes, think about this 0.91 degrees. How can I convert that over to minutes? So let's multiply this by 60 minutes over 1 degree. So remember, these are equal here, so this is a complex form of 1. This is called a unit fraction. So this unit here would cancel with this unit. The units you don't want, you always put that in the denominator. And you end up with 0.91 times 60 minutes, which would give us 54.6 minutes. Now again, you're going to just take what occurs to the left of this decimal point. So I want to put 54 for 54 minutes in there. And then I'm going to take that 0.6. Let me get rid of this. I'm going to take that 0.6 minutes and I'm going to convert that over to seconds. So there are 60 seconds in 1 minute. So we're going to say this is multiplied by, so I'm going to put 1 minute down here, and up here I'll put 60 seconds like this. Now, this will cancel here. So what you get is 0.6 times 60 seconds, and that's going to give you 36 seconds. Okay, so not bad overall. Let's put the 36 up there. And so the answer that we get is 55 degrees, 54 minutes, and then 36 seconds. So this guy right there. All right, for question 5, we are asked to state if the two angles are coterminal angles. So coterminal angles are two angles that are in standard position, and they have the same initial side and the same terminal side. So the amount of rotation is going to differ by some multiple of 360 degrees. So in this case, you could just subtract, right? So it doesn't matter if you do 70 degrees minus 270 degrees, or if you do 270 degrees minus 70 degrees. The positive or negative doesn't matter. You're just looking for, is it a multiple of 360 degrees? So let's say we had 270 degrees minus 70 degrees. That's 200 degrees. That is not a multiple of 360 degrees. So the answer here is no. These are not coterminal angles. All right, for question 6, we're asked to find a coterminal angle between 0 degrees and 360 degrees. So we are given negative 390 degrees. For this, you have to just add 360 degrees continuously until you get into this between 0 degrees and 360 degrees. So you're going to have to add it twice, or basically add 720 degrees. If you do this, you're going to end up with 330 degrees. So in other words, start with negative 390 degrees, add 360 degrees, you get to negative 30 degrees. Then add another 360 degrees, you would get to 330 degrees. So this is what you're looking for right there. All right, let's take a look at question 7. So we want to find the measures of the marked angles. And we are told that M and N are parallel lines. So here's line M, here's line N. So we know from the lesson that we have these 8 angles that are formed. You can go through and number them, but it's not really necessary in this case. We're just trying to find the measure of this angle here and this angle here. So what could we say? We know that the measure of this angle right here and the measure of this angle right here, those are alternate exterior angles. So the measure is going to be the same. So I could put in here a 7x plus 10, that quantity degrees. So that's one way to do it. And then you would think about this angle here that includes this guy plus this guy. That's going to be a straight angle, which is 180 degrees. So really all you have to do for this problem is sum these guys and say that 7x plus 10 plus the 4x minus 17. Forget about the degree symbol for right now. This is going to be equal to 180. And so 7x plus 4x is 11x. 10 minus 17 is negative 7. This equals 180. Let's add 7 to both sides of the equation. This cancels. You get 11x is equal to 180 plus 7 is 187. Let's divide both sides of the equation by 11. Let's cancel this with this and say x is equal to 187 divided by 11 is going to be 17. Let's get rid of everything here. And all we need to do is plug in. So you have 7x plus 10, that quantity degrees. 7 times for x, I have a 17. 7 times 17 is going to be 119. Then plus 10, that's going to be 129. So the measure of this angle is 129 degrees. Now again, the measure of this angle plus this angle is 180 degrees. So you could say 180 degrees minus 129 degrees. That's going to be 51 degrees. So let's just say that this is 51 degrees. Okay. Now, you could have also plugged in 4 times 17, that's 68, and then 68 minus 17 is going to be 51. So that's another way to do it. Now, if you wanted to, you can go through and get all the angles here. We know that this guy and this guy, those are vertical angles, so they have the same measures. This is 129 degrees here. And so this guy and this guy, those are vertical angles, so this is 51 degrees here. Now, with this guy and this guy, these are alternate exterior angles, so they have the same measure. So this is 129 degrees. And then these are vertical angles, so this is 129 degrees. Or you could say that this guy and this guy are alternate interior angles. They have the same measure. So lots of ways to get all these angle measures. And so this guy and this guy, those are alternate exterior angles. So this would be 51 degrees. It would have the same measure as this one. And then these are vertical angles. So this is 51 degrees as well. Or you could say that this guy and this guy are alternate interior angles and they have the same measure. So whatever you want to do. But for the answer for this specific problem, you're going to say it's 129 degrees for this guy and then 51 degrees for this guy. So let's come down here. We're going to answer this one. So 129 degrees and then 51 degrees. All right, for question 8, we're asked to find the unknown angle measures. So for angle 1, which is this guy right here, it's 5x plus 37, that quantity degrees. For angle 2, this guy right here, it's the quantity 2x minus 15 degrees. And for angle 3, this guy right here, it's 18 degrees. Well, we know if we sum the measures of all the angles in a triangle, we're going to get 180 degrees. So we can just say that this is 5x plus 37. Forget about the degrees for right now. Then plus 2x minus 15. Again, forget about the degrees for right now. Plus 18 is equal to 180. So you have 5x plus 2x, that's 7x. And then 37 minus 15, that's 22. And then plus 18, that's going to be 40. So you have 7x plus 40 is equal to 180. Let's subtract 40 away from each side of the equation. This cancels. We're going to get 7x is equal to 180 minus 40 is 140. Let's divide both sides of the equation by 7. This cancels. We get x is equal to. With these types of problems, you do need to plug back in. You can't answer x equals 20. That doesn't make any sense. You're looking for the angle measures. Okay, so let's put this up here. We know for angle 3, it's 18 degrees. So you could just copy that if you want. You could put that the measure of angle 3 is equal to 18 degrees like that if you wanted to. Let's put the measure of angle 1 is equal to, you have 5 times x. Now x is 20, so 5 times 20 is 100. Then plus 37 is 137. So this is 137 degrees. And then the measure of angle 2 is going to be equal to, here it's 2 times 20, which is going to be 40. And then minus 15, which is going to be 25. So that's 25 degrees. So let's copy these and paste this in here. So for angle 1, I'm looking for 137 degrees. For angle 2, I'm looking for 25 degrees. And for angle 3, I'm looking for 18 degrees. So that guy right there. All right, let's take a look at question 9. So we're asked to find the unknown angle measures. And we're told that triangles ABC and DEF are similar. So angle A has a measure of 77 degrees. So that means the corresponding guy, which is D, also has a measure of 77 degrees. And then we have that angle E has a measure of the quantity 15x plus 5 degrees. So angle E and angle B, those are corresponding angles. So they're going to have the same measure. And then angle C has a measure of the quantity 14x plus 11 degrees. And so angle C and angle F, those are corresponding angles, so they have the same measure. Now at this point, we know that the measure of angle A is 77 degrees. And again, the corresponding angle is angle D. So I'm just going to put a comma and put the measure of angle D is going to be 77 degrees as well. So how do we figure out B and E? Those are corresponding. So let me put B here equals what? Let's put E here equals what? And then also we need C and F. So let me put C here equals what? And F here equals what? Those are corresponding as well. Now, we know that if we just start with one triangle, doesn't matter which one, and we go around and we think about the measures of all the angles, well, the sum is 180 degrees. Well, I have the measure of angle A, that's 77 degrees, plus the measure of angle B is not given, but the corresponding guy, which is E, I have an expression for that. So let's put 15x plus 5. Forget about the degree symbol for right now. I'm actually going to erase it from there. We don't need that. Let's put plus. Then the other guy is going to be C. Now C, it's told to us here, has a measure of this 14x plus 11, again, this quantity degrees, but just take the 14x plus 11. Let me grab this, and let's come to a fresh sheet and say this equals 180 for 180 degrees. So if we do 15x plus 14x, that's 29x. 77 plus 5 is going to be 82. And then 82 plus 11 is going to be 93. So let's add 93 here. Set this equal to 180. Let's subtract 93 away from each side of the equation. So this is going to cancel. Let's say that we have 29x is equal to 180 minus 93. That's going to give me 87. If I divide both sides of the equation by 29, this cancels and we get x is equal to 87 divided by 29 is 3. So coming back here, we have that x is equal to 3. Let me make that 3 a little bit better. Okay, so for angle E, it's 15 times x, x is 3. So 15 times 3 is 45, plus 5 is going to be 50. So it's 50 degrees. So for angle E, the measure is 50 degrees. And that's also true for angle B, right? Those are corresponding angles, so they have the same measure. Now, at this point, you could plug in, or you could just say, well, 77 degrees plus 50 degrees, that's 127 degrees. And then 180 degrees minus 127 degrees would be 53 degrees. So for angles C and F, it's going to be 53 degrees, right, in each case. Now, you could have also plugged in 14 times 3, that's 42. Then plus 11, that would get you to 53 degrees as well. Okay, let's grab this. And looking at our answers, we want to say that the measure of angles A and D, that's going to be 77 degrees. Then the measure for angles B and E, that's going to be 50 degrees. And then the measure for angles C and F, that's going to be 53 degrees. So I want this guy right there. All right, for question 10, we want to use the given point on the terminal side of angle theta to find the value of the trigonometric function indicated. So we're trying to find cosecant of theta, which by definition is going to be the reciprocal of the sine of theta, right? The sine of theta is y over r, so the cosecant of theta is going to be r over y. So if we look at the point that we're given, it's x comma y. So the x value here is the square root of 19, and the y value here is negative 9. So I can plug this negative 9 in right now. For the r value, I get that from the square root of x squared plus y squared. So r is equal to the square root of, if I square x, that's going to be the square root of 19 squared, that's 19. Then plus, if I square y, negative 9 squared is going to be positive 81. So 19 plus 81, that's going to be 100. So if you took the principal square root of 100, you would get 10. So r, let me write that over here, r is equal to 10. So I can just put a 10 up here, and you could move the negative out in front if you want to do that. The cosecant of theta is going to be equal to the negative of 10 ninths. So we want this answer right there. Okay, let's look at question 11. So we want to use the given point on the terminal side of angle theta to find the value of the trigonometric function indicated. So we are trying to find the sine of theta, which remember is y over r, given this point here where the x value is negative 9 and the y value is 18. So again, you could just plug in what you have. I know that's 18. I don't know what r is, but again, you could just say r is equal to the square root of x squared. So x is negative 9. If you square negative 9, you get 81. Then plus y squared, y is 18. If you square 18, you get 324. So 81 plus 324, that's going to be 405. So you would just want to break this up. So I know 405 is divisible by 5, so start with that. So that would give you 5 times 81. So let's say this is 5 times 81. And 81 is a perfect square, right? It's 9 times 9. So this is 9 times square root of 5. This is 9 times square root of 5. Okay, let me put a comma there. And let's put that in here as 9 times the square root of 5. We're going to cancel a common factor of 2 between numerator and denominator. 18 divided by 9 is 2. So this becomes 2 over the square root of 5. But we know from basic algebra that we always want to rationalize the denominator. So I'm going to multiply this by the square root of 5 over the square root of 5. So this gives me 2 times the square root of 5 over 5. So that's going to be for my sine of theta. If you want, you could erase this, but it's just scratch work. So I'm just going to grab this answer right here. So 2 times square root of 5 over 5. Okay, let's take a look at question 12. So we want to find the tangent of theta. Let me write that out. So the tangent of theta, which we know is y over x, if its terminal side is defined by the given ray. So we have negative 5x minus 7y equals 0, where x is less than or equal to 0. So you can't pick 0 for x, but you can pick anything else that does not violate that statement there. So I'm just going to make this easy and pick x equals negative 7. Okay, I have to choose something where x is less than 0. Okay, it can't be 0 itself. That's not going to work. So I'm just going to pick something, again, just x is equal to negative 7. You could pick whatever you want. You could pick x equals negative 2 trillion, right? As long as it doesn't violate this and it's not 0, you're okay. So I'm just going to plug in. So negative 5 times negative 7, then minus 7y is equal to 0. So this is going to be 35. So 35 would be equal to, move this over here by adding 7y to both sides, and just divide both sides by 7. So y here is going to be 35 over 7, which is 5. So y is 5 when x is negative 7. Okay, now we have our point on the terminal side. So again, you just plug in. So here it's y over x. So for y, it's a 5. And then for x, it's a negative 7. And you could put the negative out in front. So my tangent of theta is going to be negative 5 over 7. So this guy right there. All right, let's take a look at question 13 now. We want to find the cotangent of theta. So the cotangent of theta, which we know is x over y. It's the reciprocal of the tangent of theta, which is y over x. Given that the secant of theta is negative 5/3 and the sine of theta is positive. So first off, the secant is going to be the reciprocal of the cosine, right? So those guys are negative in quadrants 2 and 3. And then for sine, it's positive in quadrants 1 and 2. So we know that theta is in quadrant 2. Okay, so we know that. So for cotangent, it's actually going to be negative in quadrant 2. Okay, so we know that. All right, so thinking about this, there are many ways that you could do it. You could use an identity if you wanted to. I think probably it's just easier to say that the secant of theta is equal to the r value over the x value. And in this particular case, we have the negative of 5/3. We know that r is not going to be negative. So I'm just going to say that r is equal to 5. And then I'm going to say that x is equal to negative 3. And that's consistent with being in quadrant 2, right? In quadrant 2, we're going to have x values that are negative. So we can get our y value that we need for this guy right here by just plugging in. We know that r is equal to the square root of x squared plus y squared. Or you could say r squared is equal to x squared plus y squared like this, right? Just squaring both sides. So in this case, r is 5. So if I squared 5, I'd get 25. And we know that x is negative 3. If I squared negative 3, I would get 9. And so I think you can see that your y value is going to be 4. Because again, forget about the fact that this is negative. You're thinking about a 3, 4, 5 right triangle. Okay. But again, for completeness, if we subtract 9 away from each side, you would have 16 is equal to your y squared. And so if you solve for y by the square root property, y equals plus or minus the square root of 16, which is 4. Now, we are in quadrant 2, And in quadrant 2, the y values are positive. So I want 4 there. And so let me put y equals 4. And so we basically have enough to fill in this guy right here. The cotangent of theta is x, which is -3, over y, which is 4. So you can put the negative out in front if you want. We're looking for -3/4. So this guy right here, that's your cotangent of theta. Okay, let's look at question 14 now. So again, we want to find the secant of theta. So the secant of theta, remember this is the reciprocal of the cosine of theta. So instead of x over r, which is your cosine of theta, it's going to be r over x. So we are given that the sine of theta is positive. It's square root of 2 over 2. And the cosine of theta is positive. So for sine, it's positive in quadrants 1 and 2. Cosine is positive in quadrants 1 and 4. So we know that theta is in quadrant 1. Okay. Now, when we think about this, we have our sine of theta, which is y over r, which in this case is the square root of 2 over 2. So let's take y as the square root of 2 and r as 2. So let's say that our y value is the square root of 2. And let's say our r value is 2. And again, you can just plug in and solve for x that you're going to need here. So you'd say that r squared, so 2 squared is 4, is equal to x squared plus y squared. Now, y is the square root of 2. So the square root of 2 squared is 2. Subtract 2 away from each side. You're going to have x squared is going to be equal to 2. And just use your square root property. So x is equal to plus or minus the square root of 2. We're in quadrant 1, so I just want the principal square root of 2. So x is equal to the principal square root of 2. So for this one, for the secant of theta, it's r. Secant of theta is r, which is 2, over your square root of 2. So let's rationalize the denominator. So I'll multiply this by the square root of 2 over the square root of 2. So this gives me 2 times the square root of 2 over 2. Now I can cancel this 2 with this 2, and I'm left with a final answer here, which is just the square root of 2. So I'm looking for this guy right here. So the secant of theta is just going to be the square root of 2. All right, for question 15, we want to use identities to find the value of each expression. We want to find sine of theta and cotangent of theta. Okay, we're given that the cosine of theta is 4/7 and that the sine of theta is greater than 0 or positive. So for sine to be positive and cosine to be positive, we have to be in quadrant 1. So theta is in quadrant number 1. Okay. Now you can use the identity that says that sine squared theta plus cosine squared theta is equal to 1. We're given cosine of theta. It's 4/7, but you need to square it. Okay. So if I square 4, I get 16. If I square 7, I get 49. So this is 16 over 49. So let's say that sine squared theta is equal to 1, which I'm going to write as 49 over 49. So I have a common denominator minus this 16 over 49. Let's get rid of this so we can stay on this page. And I'm just going to say that 49 minus 16, that's going to be 33. So this sine squared theta is equal to 33 over 49. Okay, let's get rid of this. If you use your square root property, you're going to say that the sine of theta is equal to plus or minus the square root of this 33 over 49. Now we know we want the principal square root because we're in quadrant 1. And we know this is the square root of 33 over the square root of 49. And so the square root of 49 is 7. So this is my sine of theta. It's the square root of 33 over 7. Now, that's not the full answer because we also need the cotangent of theta. So let me get rid of this. And let me move this up here. We know from the quotient identities that if we have the tangent of theta, this is the sine of theta over the cosine of theta. Now, if you have the cotangent of theta, it's just the reciprocal of this. So you could say the cotangent of theta is equal to the cosine of theta over the sine of theta. Okay, or you could find the tangent of theta and flip it. I mean, there's so many ways to do these things, it's not even funny. So what I'll do here is I'll just take my cosine of theta, which was given. So we'll go cotangent of theta is equal to 4/7. And then I'm going to multiply by the reciprocal of the sine of theta. okay, just to get this. So I'm just going to flip this guy and say this is 7 over the square root of 33 like this. And so this would cancel, and I'm left with 4 over the square root of 33. I would multiply by the square root of 33 over the square root of 33, and I would get 4 times the square root of 33 over 33. So I am looking for a sine of theta that is the square root of 33 over 7. So that's going to occur here, and let's see, also here. And then I'm looking for a cotangent of theta, which is 4 times square root of 33 over 33. So not this one, but this one, right? So this is exactly what I'm looking for. So my sine of theta is the square root of 33 over 7. My cotangent of theta is 4 times the square root of 33 over 33. All right, let's take a look at the quiz. For the first question, we're asked to find the secant of theta for this guy right here. So I want you to recall that if you're looking at this triangle here, this guy right here is your 90-degree angle. And then opposite of that is your hypotenuse. Okay, so this right here, I'm just going to write HYP for hypotenuse, and maybe off to the side we'll put HYP is equal to, the length we're given is 2 times square root of 13. Okay, let me make this P a little bit cleaner there. Now we're dealing with this angle theta. Okay, so opposite of the angle theta is going to be this side here. So let me put that this is OPP for opposite. And in this particular case, the length given is 6. Okay, so the final side is this guy right here, and this is adjacent to our angle theta. So let me put ADJ here. The length is given as 4, and let me label that ADJ here. Okay, so if we're trying to find the secant of theta, remember the secant of theta is the reciprocal of the cosine of theta. And the cosine of theta, again, if you use the SOHCAHTOA to remember this, well, you look for the C, and it's adjacent over hypotenuse. So for cosine of theta, it's adjacent over hypotenuse. If you want the secant of theta, just flip that. It's hypotenuse over adjacent, okay? So in this particular case, let me get rid of all of this because I'm only looking for this. We will just say that the secant of theta is equal to your hypotenuse over your adjacent. So your hypotenuse is 2 times the square root of 13 over your adjacent, which is 4. You can cancel a common factor of 2 between numerator and denominator. So this would be a 2 down here. And let me write this as the square root of 13 over 2. So I'm looking for my secant of theta is equal to the square root of 13 over 2. Okay, let's look at question 2. So we want to find the cosecant of theta given this guy right here. So again, this is your 90-degree angle right here. Maybe I can make that a little bit cleaner. So this is your 90-degree angle. And opposite of that is this guy right here. That's your longest side or your hypotenuse. I'm just going to put HYP. So HYP, we're going to put the length for that is 18. Okay. We're dealing with this angle theta right here. And so the side opposite of theta is going to be this guy right here. So let me put OPP for opposite. And that's going to be for the length, it's 5 times square root of 11. And then for this guy right here, this is the adjacent side. And the length given there is going to be 7. So if we want the cosecant of theta, remember this is the reciprocal of the sine of theta. Okay, so again, if you write out the SOHCAHTOA, okay, that we should remember by now, then basically for sine, it's O and then H, so opposite over hypotenuse. So opposite, let me write this out. So sine of theta is opposite over hypotenuse. Well, I don't want the sine of theta. I want the cosecant of theta, and that is the reciprocal of the sine of theta. So it's going to be hypotenuse over opposite. So hypotenuse over opposite. Let me drag this up here. And you can just fill this in. So the hypotenuse is 18, and the opposite is going to be 5 times the square root of 11. Now we want to rationalize our denominator. So let's multiply this by the square root of 11 over the square root of 11. So this would be equal to 18 times the square root of 11 over, you have 5 times square root of 11 times square root of 11. That's 5 times 11, which is 55. Okay, you can't make that any simpler. So I'm looking for my cosecant of theta to be equal to 18 times the square root of 11 over 55. So this guy right there. All right, let's take a look at question 3. So we want to write each function in terms of its cofunction. So we have the cosecant of 73 degrees. And so remember, if we have the cosecant of some acute angle, in this case it's 73 degrees, we can say this is equal to the cofunction here is going to be secant. So this is the secant of, you would say 90 degrees minus this angle measure here, which is 73 degrees. Let's make this 3 a little bit cleaner. And so 90 degrees minus 73 degrees is 17 degrees. So I can just erase this and put 17 degrees here. So you could say the cosecant of 73 degrees is equal to the secant of 17 degrees. So looking through my answers, I'm going to want to select this one where it says the cosecant of 73 degrees is equal to the secant of 17 degrees. Okay, let's take a look at question 4. So we want to find one solution, and we're going to assume that all angles are acute. So what we have here is the sine of 4 theta minus 7 degrees is equal to, we have our cosine of 9 theta minus 33 degrees. So we know the relationship is such that this guy plus this guy is 90 degrees. Because again, if you have sine of some acute angle, let's call it theta, this is equal to the cosine of 90 degrees minus that angle theta. So this guy plus this guy would give me 90 degrees. So what I'm going to do is set myself up a nice little equation and say 4 theta minus 7 degrees plus 9 theta minus 33 degrees is equal to 90 degrees. All right, so 4 theta plus 9 theta would be 13 theta. And then negative 7 degrees minus 33 degrees would be negative 40 degrees. And this equals 90 degrees. Let's add 40 degrees to each side of the equation. So this would cancel. You have 13 theta is equal to 90 degrees plus 40 degrees is 130 degrees. Let's divide both sides of the equation by 13. This would cancel, and you get theta is equal to, for 130 degrees divided by 13, that's going to be 10 degrees. So coming back up here, I just want to circle that theta is equal to 10 degrees. And again, you can always plug this in and verify. 4 times 10 degrees would be 40 degrees. 40 degrees minus 7 degrees would be 33 degrees. So sine of 33 degrees is equal to the cosine of 9 times 10 degrees would be 90 degrees. And then 90 degrees minus 33 degrees, which is what you have over here for the 33 degrees, that's going to give you 57 degrees. So these two would be equal because, again, the sum of this and this would be 90 degrees, right? So the sine of 33 degrees is equal to the cosine of 57 degrees. Okay, let's look at question 5. We want to find one solution. Again, we will assume all angles are acute. Just like in the last example, this guy plus this guy is going to give us 90 degrees. So we have the cotangent of 7 theta plus 2 degrees is equal to the tangent of 6 theta minus 3 degrees. And again, if you see this in your book, it'll say cotangent of theta is equal to the tangent of your 90 degrees minus theta. So this guy plus this guy is going to give you 90 degrees. Again, I'm just going to use that relationship to say that this guy plus this guy is 90 degrees. So 7 theta plus 2 degrees, then plus 6 theta minus 3 degrees is equal to 90 degrees. Okay, so 7 theta plus 6 theta is 13 theta. So let's write 13 theta. And then 2 degrees minus 3 degrees is negative 1 degree. So let's put minus 1 degree like this. This equals 90 degrees. Let's add 1 degree to both sides of the equation. That cancels. You get 13 theta is equal to 90 degrees plus 1 degree is 91 degrees. Let's divide both sides of the equation by 13. And so this right here is going to cancel. You'll get theta is equal to, if I think about 91 degrees divided by 13, that's going to give me 7 degrees. So coming back up, I want to select that theta is 7 degrees. And again, you can always plug in. So 7 times 7 degrees would be 49 degrees. And then 49 degrees plus 2 degrees is going to be 51 degrees. So the cotangent of 51 degrees is equal to the tangent of, well, this is going to have to be 39 degrees for this to be true. So let's plug in and see if it is. So 6 times 7 degrees is 42 degrees, and 42 degrees minus 3 degrees does give me my 39 degrees that I need. So this is a true statement. All right, let's take a look at the quiz. For the first question, we're asked to find the reference angle. And this angle here we're given is 410 degrees. So because our measure is greater than 360 degrees, we want to find our coterminal angle that's between 0 degrees and 360 degrees. So you would start by just saying 410 degrees minus 360 degrees is going to be equal to 50 degrees. Now, when you think about a 50-degree angle, that's going to be in quadrant 1. So just come over to your little cheat sheet, and for your reference angle, your theta prime, which is your reference angle, is equal to theta. So your reference angle here is equal to your 50-degree angle, your coterminal angle with a 410-degree angle. So it's just going to be 50 degrees for your theta prime or your reference angle. Okay, let's look at question 2. So again, we want to find the reference angle, and now we have a negative 545-degree angle. So again, if it's negative like this, you're going to have to add some multiple of 360 degrees to get yourself into the range where you're between 0 degrees and 360 degrees. So I'm going to add 720 degrees here, and that's going to give me 175 degrees. So we know that this is going to be in quadrant 2. And so in quadrant 2, I'm going to use this formula here. So theta prime is equal to, you're going to have your 180 degrees minus your theta, which here is 175 degrees. So that's going to be 5 degrees. So I'm looking for this answer right here. We would have a reference angle or your theta prime of 5 degrees. Okay, for question 3, we want to find the exact value of each. And we have the tangent of negative 1020 degrees. And so for this one, again, first, find the coterminal angle that's going to be between 0 degrees and 360 degrees. So you have negative 1020 degrees. You're going to need to add 360 degrees, another 360 degrees, and then another 360 degrees. So 3 times 360 degrees is 1080 degrees. So we say plus 1080 degrees. So this is 60 degrees. So I'm going to work with this guy right here. And a 60-degree angle is its own reference angle. Okay, so you're just going to work with 60 degrees. Now, if we think about being in quadrant 1, everything's positive. So all I really have to do is say this is equal to, let's get rid of this, the tangent of 60 degrees. So looking here, so my tangent of 60 degrees, this is going to be the square root of 3. So coming back up, I just want to say it's the square root of 3. Okay, for question 4, we want to find the exact value of each. So we have the secant of negative 870 degrees. And so let me write that out. So the secant of negative 870 degrees. So for this one, I'm going to take negative 870 degrees, and I'm going to add 360 degrees, another 360 degrees, and another 360 degrees, or again, 1080 degrees. And that's going to give me 210 degrees. Okay, so for this guy, we are going to be in quadrant 3. So for secant, which is the reciprocal of cosine, that's going to be negative in quadrant 3. Okay, so keep that in mind. So we would think about the reference angle here. So in quadrant 3, 210 degrees minus 180 degrees is going to be 30 degrees. Let's get rid of this. And I'm going to say this is equal to, again, because we're in quadrant 3, your secant is going to be negative. So the negative of the secant of your 30 degrees. And so this is the negative of, if you look at the secant of 30 degrees, it's 2 times square root of 3 over 3. So we want the negative of 2 times square root of 3 over 3. So this answer right here, we want the negative of 2 times square root of 3 over 3. Okay, let's look at question number 5 now. So we're asked to evaluate each. So we have sine squared of this 480 degrees, then plus cosine squared of this negative 1320 degrees. Let me grab this real quick and let's paste this in and let's think about this. You're going to end up with the Pythagorean identity, sine squared theta plus cosine squared theta equals 1. So I want to show you how you can do this in 2 different ways. So the first way, the shortcut would be, again, you're getting coterminal angles in each case. So for 480 degrees, you just subtract 360 degrees away. That's 120 degrees, okay? So I'm going to say this is equal to sine squared of 120 degrees. Plus, for this one, you get a coterminal angle as well. So you have negative 1,320 degrees. You're going to need to add 4 times 360. So 360 plus 360 is 720. Then plus 360 again is 1,080. Then plus another 360 is 1,440. Okay, so this is in terms of degrees. If you add these together, you're going to get 120 degrees. So you see that this is cosine squared of 120 degrees. Now, we know, again, from the Pythagorean identities, that sine squared theta plus cosine squared theta is equal to 1. So theta here is 120 degrees. 120 degrees here, 120 degrees here, right? So I have the same angle in each case. So this is equal to 1 by definition. So that's your shortcut. If you wanted to do this the long way, let me get rid of this. And let's come up here. Again, you think about 120 degrees, that's going to be in quadrant 2. Okay, so in quadrant 2, your sine is positive and your cosine is negative. And in terms of your reference angle, you're going to be looking at a 60-degree reference angle. right? Because you have 180 degrees minus 120 degrees, so your reference angle is 60 degrees. So the sine of 60 degrees is square root of 3 over 2. This would be squared. Plus, what is the cosine of 60 degrees? Well, that's going to be a half. Okay, now in this particular case, it's got to be negative 1/2 because, again, the cosine values in quadrant 2, that's going to be negative. Okay, it's not going to really change anything here because we're squaring it, but just keep in mind for accuracy, you want to make this a negative 1/2 because cosine is negative in quadrant 2. Okay, so does this equal 1? Well, we could check it. If you square the square root of 3, you get 3. If you square 2, you get 4. And then this negative would go away if you square it. And then a half squared is a fourth. So yeah, this does equal 1, right? 3/4 plus 1/4 equals 1. If we come back up here, we know the answer is going to be 1. Sine squared of 480 degrees plus cosine squared of negative 1,320 degrees is going to be 1. All right, let's take a look at the quiz. For the first question, we're asked to approximate to the nearest 10,000th. And we're given the cosecant of negative 590 degrees. So again, if you're using a calculator that has a cosecant key, just use that. Otherwise, you're going to have to say that the cosecant of this negative 590 degrees using your reciprocal identity is 1 over the sine of the negative 590 degree angle. And so I'll say that this is approximately going to be, let me key this into my calculator. I get 1.30540728.9, and then my calculator cuts off. So we are told to go to the nearest 10,000th. So let's see, that's going to be right there. So this is where we have the 10,000ths place. So look at the digit that follows, that's a 0. So basically that tells me to leave the 4 unchanged and get rid of all these. So I would have an approximate answer here as 1.3054. So looking through my answers, I want this one. So the cosecant of negative 590 degrees is going to be approximately 1.3054. Okay, let's look at question 2. So again, we want to approximate to the nearest 10,000th. So we have the secant of this 881 degrees. And again, I'm just going to rewrite this using cosine because I know we mostly have that key. So I'm going to say this is 1 over the cosine of 881 degrees, just using my reciprocal identity. So this is approximately, let me key this into my calculator. So I get negative 1.057620681. So let's see, I want to round to the nearest 10,000th. So I have the tenths, the hundredths, the thousandths, and then the 10,000ths. So then I'm looking at the digit that follows. So that's a 2. So that tells me to leave the 6 unchanged and then cut all these off. So my answer for the secant of 881 degrees is going to be approximately negative 1.0576. So this guy right here, the negative 1.0576. All right, let's take a look at question 3. So we want to approximate to the nearest 10,000th. So we have sine of negative 414 degrees. So you should have a sine key on your calculator. If you just punch this in, you're going to get approximately, let's go negative 0.809. And then I'm going to go 0.169944. Now I want to round and I have a negative number. So a lot of students get in trouble here. Again, just pretend like this is a positive number. Just use your normal procedure. Nothing's going to change. So I'm going to go 1, 2, 3, 4 decimal places because I want to round to the nearest 10,000th. And if I think about the digit there that follows, this is a 1. So I'll leave that 0 unchanged and I can cut all these digits off. But also because this guy is a 0 here, I can cut that off as well. That doesn't add any value to the number. So we would say that the answer here is negative 0.809. That's my approximate value for the sine of negative 414 degrees. So this is what I want right here. Okay, let's look at question 4. We want to approximate theta to the nearest 10,000th. And we're given that sine of theta is equal to 4 over 19. And this is the key to the problem here. We're told specifically that theta is greater than or equal to 0 degrees and less than or equal to 90 degrees. Because if you think about theta there's an infinite number of answers that would actually work, right? So an infinite number of angle measures, when you take the sine of that angle, you would get 4 over 19. So what I would do is say that the inverse sine of this 4 over 19 this is approximately 12.153, and then we have 19747. To round this, again, I'm going to go 1, 2, 3, 4 decimal places. Now, the digit that follows is going to be a 9. So I'm going to add 1 to this one. That's going to give me 2, and then cut everything else off. And this is in terms of degrees. So my approximate answer here is 12.1532 degrees. So I'm looking for this guy right here. Okay, let's look at question 5. So approximate theta to the nearest 10,000th. And we have that secant of theta is 27/8. We're trying to find theta. And given the fact that theta is greater than or equal to 0 degrees and less than or equal to 90 degrees. So we actually need this because, again, with theta, there's an infinite number of answers or angle measures there that would work. So what we would say here is, first I would convert the secant of theta equals 27/8. I would say that the cosine of theta is the reciprocal of this, so it's 8/27. And then I would say the inverse cosine of 8/27 is going to be approximately 72.7647, and then 1474. Again, thinking about 1, 2, 3, 4 decimal places, the digit that follows is a 1, so I can just cut this off and then put this in terms of degrees. So I'm looking for an answer of 72.7647 degrees. So this guy right there, that's my approximate angle measure for this theta. Again, given this, theta is greater than or equal to 0 degrees and less than or equal to 90 degrees. All right, let's take a look at the quiz. For the first question, we're asked to find theta to the nearest 10th. So here's our theta here. And what we have to work with is this side here, which is opposite of our right angle. So this is the hypotenuse. It has the length 7. And then this side right here, it's opposite of angle A. So you could call it lowercase a if you want. But we really don't need to do that here. So I'm just going to say that the sine of theta is going to be the opposite, which is this 5 over here, and then over your hypotenuse, which is going to be your 7. So now I'm going to use my inverse sine function. So I'll say that theta is equal to the inverse sine of this ratio right here, so 5/7. We're going to key that into our calculator, and I get about 45 point, if we're rounding to the nearest 10th, let's go 6, and then we'll say degrees. So our theta here is about 45.6 degrees. So I'll want this one right here. So theta is about, or you could say approximately 45.6 degrees. Okay, let's look at question 2. We want to find theta to the nearest 10th. So in this case, here's theta. So that's my angle B. You could say that as well. And I'm looking at, let's see, the hypotenuse is 12. That's opposite of my right angle, my 90-degree angle. And then opposite of my angle B, or your angle theta, whatever you want to say for that, you're going to have this side with length 9. So let's go ahead and say that this guy right here would be your opposite over your hypotenuse. So we can use sine again. So the sine of theta is going to be equal to, again, the opposite is 9. The hypotenuse is going to be 12. You could reduce that if you want. I mean, we're going to key it into the calculator, but just for completeness, let's go ahead and say this is 3/4. Just dividing each part there, the numerator and the denominator, by 3. And so what I'll have here is theta is equal to the inverse sine of this 3/4. So that's approximately, we're rounding to the nearest 10th, let's say 48.6 degrees. So 48.6 degrees. So coming down here, I want this one. So theta is approximately 48.6 degrees. Okay, let's look at question 3. So we want to find B, and that's this side length here, to the nearest 10th. All right, so we are given this side right here, which is opposite this angle A. And we have this angle measure here. And of course, we could find this angle measure here if we wanted to, but it's not necessary. What we have is this side here, and we want to find this side here. So in relation to this 55-degree angle, this guy right here is going to be my adjacent, and this guy right here is going to be my opposite. So you could say the tangent of this 55-degree angle here is equal to, again, the opposite, which is B, over the adjacent, which is 3.1. And this is something we can solve very quickly. We'll multiply both sides of the equation by 3.1. We'll clear that out. And we'll say B is equal to 3.1. Let me make this 3 a little bit cleaner here, times your tangent of 55 degrees. So let's punch that into the calculator. And if I'm rounding to the nearest 10th, I get 4.4. So we'll say this is approximately 4.4. So coming down here, we'll say B. The length of that side is about 4.4. Okay, for question 4, we're asked to find C to the nearest 10th. And c, this is lowercase c, that's this side length here. This is opposite the right angle, so we know this is the hypotenuse or the longest side. So what I would think about here, I have this 60 degrees. Of course, it's very easy to figure out that this is 30 degrees. You don't need it, but this is a 30 degree, 60 degree, 90 degree right triangle, so we all know that one. And what I would do here is just think about the fact that from this 60 degree angle, this guy right here is your adjacent, and this guy right here is your hypotenuse. So where do we have adjacent over hypotenuse? Well, that's going to be with cosine. So the cosine of this 60 degree angle is equal to, again, the adjacent, which is 4, over the hypotenuse, which is c. So what I'll do here is just multiply both sides of the equation by c. We'll cancel that away. And I'll say that c multiplied by the cosine of 60 degrees is equal to 4. To finish things up, I'm going to divide both sides of the equation by the cosine of 60 degrees. And so that's going to give me c is equal to, this cancels, 4 divided by cosine of 60 degrees. So 4 divided by cosine of 60 degrees. And if you punch this into your calculator, it's exactly equal to 8. So the length of this guy right here would be 8. So let's come down here and we'll say c is equal to 8. All right, let's take a look at question 5. So here we want to solve each word problem. So we have that the current angle of elevation of the sun is 23.4 degrees. We are asked, what is the length of the shadow cast by Larry, who is 5.75 feet tall? We want to round your answer to the nearest tenth. For this one, I definitely recommend making some sort of sketch. It's just easier to visualize what's going on. So focus on this part right here. So the angle of elevation of the sun is 23.4 degrees, and the height of Larry is 5.75 feet. So let's go down here. I have a little sketch drawn. So when we talk about the angle of elevation with the sun, your horizontal is going to be the ground. So it's the angle of elevation here that's 23.4 degrees. Your line of sight would be to the sun. Okay, so from the ground to the sun. Now, when we think about this guy, Larry, we're told he's 5.75 feet tall. So if the sun is coming down and hitting him, at the top, it's going to hit the top of his head, and it's going to come down here. So that is the point right there that we want to think about. And in terms of what we want to measure, it's the length of the shadow cast by this guy. So it's going to be this guy right here going up to his feet, you could say. And then let me draw a little right triangle in here like this. Okay, so not perfect, but I think it's good enough for what we're trying to do. So let me put this little symbol in here to say this is a 90-degree angle. And we know that this side length here, which is opposite of the 23.4 degree angle, that is 5.75 feet in terms of the length, because we're told that's his height. So what I would do here is just think about, well, I need this side right here. You could call it whatever you want. For simplicity, let's just call it x. But essentially, you have the opposite, and then here you have your adjacent. So if you have opposite over adjacent, you probably want to use tangent or cotangent. So let's go ahead and say that the tangent of this 23.4 degree angle is equal to the opposite, which is 5.75, forget about the feet for right now, over what we're trying to solve for, which is x. Now, what I could do here, if you had a cotangent button on your calculator, I don't have one on mine, you could have used the cotangent there, and it's a little bit easier to solve. But I'm just going to stick with this because most people have a tangent key. So I'm going to multiply both sides by x like this. This would cancel. And so let me say that we would have x times the tangent of 23.4 degrees is equal to 5.75. And I would divide both sides of the equation by the tangent of 23.4 degrees. This is going to be hard to fit this in here, so let me scooch this down just a little bit. So the tangent of 23.4 degrees. And of course, this is going to cancel with this. So you're going to get that x is approximately, we're just going to key in that x is equal to 5.75 over the tangent of 23.4 degrees. Let's key that into the calculator. And I get about 13.3 if I round to the nearest tenth. So let's say this is approximately 13.3, and this is in terms of feet. So let's go back up. And I want this answer here. So the length of the shadow cast by Larry, it's going to be about 13.3 feet. All right, let's take a look at the section quiz. For the first question, we're asked to find the cotangent of theta. So first and foremost, when we talk about the cotangent of theta, remember, we can first find the tangent of theta, and then we can flip that, right, or find the reciprocal. So let's think about our so, and then ka, and then toa, in case you're having trouble remembering things. The T stands for tangent, and then the O is the opposite, and the A is the adjacent. So if I wanted the tangent of theta, it's the opposite over the adjacent. And then if I wanted the cotangent of theta, remember it's the reciprocal of this, so it's going to be the adjacent over the opposite. So let's get rid of this. We know where everything is coming from. And let's slide this up here. Now, we will see that looking at this guy, that this right here, if I'm thinking about theta, this 2 here is the length of the adjacent side. So let me just plug in a 2 for that. But for the opposite, I don't have anything, right? So I have to figure that out with the Pythagorean theorem. Let's just say that this is A. We'll call this B. It really doesn't matter what you call it. I'm just going to put B here for right now. We know that this guy squared, which is 2, plus this guy squared, which we're going to say is B, is equal to the hypotenuse. Again, the hypotenuse is always the side opposite of your right angle. So it's going to be this guy right here. So it's that guy squared. So 2 times square root of 5 squared. Okay, so this is the A squared plus B squared equals C squared. All right, so 2 squared is 4. And then plus you have your B squared, and this equals square 2, you get 4. Square the square root of 5, and you get 5. So 4 times 5 is 20. And what I'll do here is just subtract 4 away from each side of the equation. This cancels. Let me actually erase this so I have enough room to just fit this here without sliding down. This will be B squared is equal to 20 minus 4 is 16. So at this point, we could just use our square root property. So B is equal to plus or minus the square root of 16. We don't need the negative part here because we're thinking about the length of this side. So we would really say that B equals the square root of 16, just the principal square root. And so that's going to be 4. So let's get rid of this. And we can get rid of this and just say that this is 4. Get rid of this and say this is 4. And we know that 2 over 4 is just a half. So the cotangent of theta here is going to be 1/2. So coming down, I want to select this answer, that my cotangent of theta is 1/2. All right, let's take a look at question 2. So we're asked to write each function in terms of its cofunction. We are given sine of 38.7 degrees. So at this point, we know that sine and cosine are known as cofunctions. And then for any acute angle, let's just say A, the cofunction values of complementary angles are going to be equal. So typically what you see is something like sine of A is equal to cosine of 90 degrees minus A, like this, okay? So here we have sine of 38.7 degrees. We'll say that's equal to cosine of 90 degrees minus 38.7 degrees. Let's just punch this into the calculator, and I get 51.3. So we'll say that the sine of 38.7 degrees is equal to the cosine of 51.3 degrees. So this is the answer I want, my cosine of 51.3 degrees. Okay, for question 3, we're asked to find one solution for each equation. We want to assume all angles involved are acute angles. So before we even do this, remember from the last problem, we just talked about this, sine and cosine are cofunctions. So if you're dealing with an acute angle, let's just call it A, cofunction values of complementary angles are going to be equal. So in other words, if you have the cosine of, let's just say A, some acute angle, this is equal to the sine of your 90 degrees minus this A. Okay, so we just talked about that a second ago. With this, when you see that you have cosine of this theta plus 4 degrees, and this equals the sine of this 3 theta plus 2 degrees. So how do you solve this? Well, basically what you're thinking about is the fact that we know that this angle right here plus this angle right here, for this to be true, they have to sum to 90 degrees, right? Because they're complementary angles. This is A and this is 90 degrees minus A. If you took this A and you added 90 degrees minus A, this is equal to what? The A minus the A is going to go away, and you just have 90 degrees. So the key to this problem is that the sum is 90 degrees. So you can say that theta plus 4 degrees plus 3 theta plus 2 degrees is equal to 90 degrees. Let me get rid of this. I'm going to try not to go to a different page. I'll just do it right here. So let me just slide this up so we have a little bit of room. And basically you have theta plus 3 theta, that's 4 theta. And then you have 4 degrees plus 2 degrees, that's 6 degrees. So let me put plus 6 degrees, and this equals 90 degrees. I'm just going to subtract 6 degrees away from each side of the equation. Let's cancel this. 4 theta is going to be equal to 90 degrees minus 6 degrees is 84 degrees. Let's divide both sides of the equation by 4. So this is going to cancel, and we're going to have that theta is equal to, if I think about 84 divided by 4, that's going to be 21, and this is in terms of degrees. So this is 21 degrees. If you want to go back and plug in, you would have the cosine of 21 plus 4 is 25. So you would basically have the cosine of 25 degrees is equal to the sine of 3 times 21, that's 63, and 63 plus 2 is going to be 65, and so we'll put 65 degrees here. And this is true. You can punch this into your calculator and verify. You can see that the cosine of 25 degrees is equal to the sine of 65 degrees. Again, it just goes back to that cosine of A is equal to the sine of 90 degrees minus A. If you did sine of 90 degrees minus 25 degrees, you'd have the sine of 65 degrees. So what I'm looking for here for my answer is that theta is going to be equal to 21 degrees. So this guy right there. Okay, for question 4, we're asked to find the reference angle. So we have negative 370 degrees. Now, some people can do it like this, but I recommend putting this in terms of the coterminal angle that's between 0 degrees and 360 degrees. So I'm not going to be able to get there by just adding 360 degrees. That would give me negative 10 degrees. So I actually need to add 720 degrees, and that's going to give me 350 degrees. Okay, so let's just say that theta is equal to 350 degrees, and this is just a coterminal angle, so the reference angle will be the same. So we're just going to work with this. Now for theta prime, remember, if we're in quadrant 4, the formula is 360 degrees minus my theta, so minus my 350 degrees. So this would be a 10 degree reference angle for my theta prime. So let's come down here. We want 10 degrees for the reference angle. Okay, for question 5, we're asked to find the exact value of each. We are given the sine of 1035 degrees. So just find the coterminal angle. I'll take 1035 degrees, and I'm going to subtract away 720 degrees, and that's going to give me 315 degrees. So I'm going to work with the sine of 315 degrees. Now, when you think about this, again, the reference angle, because you're in quadrant 4, is going to be what? Your theta prime here is going to be 360 degrees minus your theta, which is 315 degrees, which is going to be 45 degrees. So let me put here that theta prime is 45 degrees. Now thinking about the sine of 315 degrees, again, because we're in quadrant 4, we know that the sine values are going to be negative. So what we would say is that the sine of 315 degrees is equal to the negative of the sine of 45 degrees, okay? So we can actually get rid of this. And even if you wanted to make this more clean, you could say that the sine of 1035 degrees, I guess you don't need the parentheses there, is equal to the sine of 315 degrees, which is equal to the negative of the sine of 45 degrees. Let me put equals here. We know the sine of 45 degrees is the square root of 2 over 2. That's something you should have memorized. So we'll just say this is the negative of the square root of 2 over 2. So looking through, I want this guy right here. So the negative of the square root of 2 over 2. Okay, for question 6, we're asked to find the exact value of each. And we have the secant of this negative 240 degrees. Again, I would find the coterminal angle here. So let's go 360 degrees minus 240 degrees. So this would be what? This would be 120 degrees. So that's your coterminal angle. So let me just start by just saying this is equal to the secant of 120 degrees. Now this 120 degree angle is in quadrant 2. So in quadrant 2, secant and also cosine, which is the reciprocal of secant, they're going to be negative. So let's put the negative of the secant of, what's my reference angle here? I'm in quadrant 2. So in quadrant 2, my theta prime is equal to 180 degrees minus my theta. In this case, it's 120 degrees, which is going to be 60 degrees. So I just want to put the negative of the secant of 60 degrees. Now, maybe you have not memorized the secant of 60 degrees, but hopefully you've memorized that the cosine of 60 degrees is going to be a half. So for the secant of 60 degrees, you just flip that and you get 2. So this is equal to, don't forget the negative, so negative 2. So going through here, we want negative 2 as our answer. Okay, let's look at question 7. So here we're asked to evaluate each. So let me write this in a different way. I'm going to say we have the cotangent of 135 degrees. And I'm going to wrap this like this and square it for clarity. Then minus, we have our sine of 30 degrees. And then plus, we have 4 times the tangent of 45 degrees. So let me actually grab this. First and foremost, let's work this one out. So if I think about 135 degrees, I'm in quadrant 2. So my theta prime here is 180 degrees minus 135 degrees, which is going to be 45 degrees. So that's my reference angle if I have a 135 degree angle. Now, the cotangent function is going to be negative in quadrant 2. Okay, so it's going to be negative in quadrant 2. So let me get rid of this. And I'm going to first just say that this is the negative of the cotangent of 45 degrees here, and this is squared. Now, what is the cotangent of 45 degrees? Well, remember, the tangent of 45 degrees is 1, so the cotangent of 45 degrees is also going to be 1. So basically, you could replace this with just negative 1. So let's just say this is negative 1, and let's tighten that down. So this is negative 1 being squared, then minus, for the sine of 30 degrees, I think we all know that that's 1/2 or 0.5 at this point. And then plus you have 4 times the tangent of 45 degrees. So again, we know the tangent of 45 degrees is 1. So 4 times 1 is just 4, but we can just write it out just for clarity. So let's put equals. And here, negative 1 being squared with the negative being wrapped inside of the parentheses, this is positive 1. So then let me actually write this next to it. So 4 times 1 is 4. So let me put plus 4 and then minus 1/2. So this would basically be 5 minus 1/2. And if you get a common denominator here, you could multiply this by 2 over 2. So you would basically have 10 minus 1 over the common denominator of 2. So this ends up being 9/2, or if you're working on a calculator, 4.5. So coming back up here, this is what we want. So 9/2, or again, if you want to answer 4.5, if you're self-studying, that's fine too. Okay, for question 8, we're asked to approximate to the nearest 10,000th. So we have the cosecant of negative 1,062 degrees. Now, some calculators will have a cosecant key. My calculator does not. I'm using the TI-84 right now. So what I would have to do is say that the cosecant of this negative 1,062 degrees is equal to, again, in terms of cosecant, remember, it's always going to be the reciprocal of your sine function. So we could say this is 1 over the sine of this negative 1,062 degrees. So this is something you can punch into your calculator. That's what I'm going to do here. And I get about 3.23 and then 606. Let me just stop there. It wanted us to round to the nearest 10,000th. So tenths, hundredths, thousandths. Here's the 10,000ths place. So you go 1 digit to the right. So this is a 6. So that means right here, I'm just going to add 1. And then everything that follows, you can just cut it off. So this is approximately 3.2361. So this guy right here. So 3.2361. All right, let's take a look at question 9. So we're asked to approximate theta to the nearest 10,000th. And we're told that cosine of theta equals 1/3, and that theta is greater than or equal to 0 degrees and less than or equal to 90 degrees. So we don't fully understand the inverse cosine function yet. But what we have talked about is the fact that if I have cosine of theta, and this equals 1/3, if I did the inverse cosine of this 1/3 here, I am going to get this theta back. Now, as we progress through the course, we'll talk more about this. For right now, because we've said that theta is greater than or equal to 0 degrees and less than or equal to 90 degrees, and this value here, this 1/3 is positive, we're going to be okay in this situation. Later on, we'll talk about other situations. So I'm just going to key this into my calculator. Let me get rid of this and just put approximately, because we're going to have to round. And I get about 70 point, let's say 52877. And we'll just cut it off there. We want the nearest 10,000th. So 1, 2, 3, 4. And I'm going to look at this 7 here. So that tells me I'm going to get rid of this, add 1 to that. So this is going to be an 8, and this is in terms of degrees. So it's approximately going to be 70.5288 degrees. So this guy right here, that's my theta. So approximately 70.5288 degrees. Okay, let's look at question 10. So we want to solve each word problem. Here we have the length of the shadow of a building, 34.09 meters tall, is 37.62 meters. Find the angle of elevation of the sun to the nearest 100th of a degree. It's probably a good idea just to make a little sketch so we can identify what's going on. So we're trying to figure out this theta here, which is the angle of elevation. Remember, this right here is the horizontal. This is your angle of elevation, so going up to this sun here. So let's come back and think about what we need to fill in. So it says the length of the shadow of a building, 34.09 meters tall. So coming back up here, this height right here would be 34.09 meters. So let me just put that in real quick. And so this, I'm just going to arrow to this. This would be 34.09, and this is in terms of meters. I'm just going to put M to abbreviate. So that's for this guy right here. That's the length. Now, we're also told the length of the shadow, and it says it's 37.62 meters. So that's from right here to right here. Let me do that in a different color. So this is 37.62 meters. Now, you could solve this triangle. We're talking about this triangle right here that I just set up, but you really don't need to. All you need to do is figure out what is theta. And for that, you think about the fact that you have the opposite and you have the adjacent, right? So this is the hypotenuse here. We don't know what it is. We could use the Pythagorean theorem and figure it out, but we don't even need it, right? We're just going to use our tangent. So remember, the tangent of theta is equal to the opposite, which in this case, this side right here, we know that's 34.09 meters. Let's just put 34.09 over the adjacent, which in this case is going to be 37.62. So 37.62, and of course it's in terms of meters, but just get rid of that for right now. And so in order to find theta, again, because this is going to give me something that's going to be in quadrant 1, we're just going to say the inverse tangent of this right here. So this 34.09 over this 37, let me make this 3 better, it's not legible, 0.62, and this is approximately, I get 42.181, and then I get 8.2. So let me cut it off there. We wanted the nearest hundredth, so that's going to be tenths and then hundredths. So if you think about it, the digit that follows is a 1, so you can just cut these off and put this guy right here. So this angle theta here is about, or approximately, 42.18 degrees. So coming back up here, the angle of elevation is going to be about 42.18 degrees. All right, let's take a look at question 11. So we want to solve each word problem. So here we have another shadow word problem. So the shadow of a vertical tower is 40.6 meters long when the angle of elevation of the sun is 34.6 degrees. Find the height of the tower, and then we're going to round your answers to the nearest tenth. So the angle of elevation of the sun is 34.6 degrees. So if you look at our little sketch here, again, this is the horizontal, your angle of elevation for this guy right here going to the sun, that's 34.6 degrees. So we have that. The length of this right here for your shadow, it's 40.6 meters in terms of the length. So let's put 40.6. You could put meters there. I'm just going to draw this in so we know what we're looking at. And then, of course, for the height, let's just go ahead and use this right here. And let me connect this a little bit better. So this would be my right triangle. So basically what I have here, if I'm solving this right triangle, right now I have an angle and I have a side. Okay, so what I could do if I wanted to get this guy right here, which is the height, well, that's my side opposite, right? And I know that I have my side that's adjacent. So if I think about opposite and I think about adjacent, I'm going to use tangent, right? So again, the tangent of theta is your opposite over your adjacent. So here we could say that the tangent of 34.6 degrees is equal to the opposite, which is unknown. Let's just call this h for height. So I'll put h over, in this case, you're going to have 40.6 meters. Just leave the meters off for now. We don't really need it. And if you want to solve for h, you would say that that's equal to, I'm going to multiply both sides by 40.6. So 40.6 times the tangent of 34.6 degrees. So if I key that into my calculator, it's approximately 28.008. And again, this is going to be in terms of meters. So you could say this is approximately 28. And we want it to round to the nearest tenth. So if I do that, it's just going to be 28. So let's just put 28 meters here. And going back up, you would just want to select this answer right here, which would be 28 meters. Again, that's rounded to the nearest tenth. All right, let's take a look at question 12. So here we have that triangle ABC is a right triangle where angle C is a right angle. A, and this is lowercase a, so that's for a side. This is the side across, so you could say opposite from angle A, and has a measure of 2.8. C, and this is lowercase c, so again, that's a side. This is the side across, so you could say opposite from angle C, and has a measure of 5. So if you're opposite of the right angle or the 90-degree angle, that's your hypotenuse. We're asked here, what is the measure of angle B rounded to the nearest tenth? So that's all we need to figure out. What is the measure of angle B? Again, rounded to the nearest tenth. So that's what we're going to focus on. Now, you could solve this without a sketch, but if you get this type of problem, I would just make a sketch. It doesn't need to be perfect. I did draw this with a computer, but if you just took a pencil and paper and just drew a rough sketch, it would work just fine. So thinking about this, we already know from the information given that opposite of this right angle, which is angle C, this is the hypotenuse and the length is 5, right? So this side, you can name it as lowercase c. And then opposite of your angle A, this side right here, we name that with lowercase a. This has length 2.8. So opposite of angle B, this would be lowercase b, but we don't really care about that. We're not trying to solve the triangle. We just want to know what is the measure of this angle right here, B. Okay, so what we can do is use this side length here and this side length here. And in terms of this angle B, this is the adjacent side, and this is going to be the hypotenuse. So if you have adjacent and you have hypotenuse, you can use cosine. So I can say the cosine of B is equal to the adjacent, which is 2.8, over the hypotenuse, which is 5. Now, because this is an acute angle, and that's going to be in quadrant 1, well, I can just use my inverse cosine function. So I can say B is equal to the inverse cosine of this right here, so 2.8 over 5. And this is approximately, let me key this into my calculator, and I get 55.944. And I'm just going to round that to the nearest tenth, so 55.9, and this is in terms of degrees. So this would be about 55.9 degrees. You don't need to fill it into the sketch. We're just going to come back up and select this. So the measure of angle B is going to be 55.9 degrees. All right, let's take a look at our quiz. For the first question, we're asked to convert each radian measure into degrees. So here we have 7 pi over 9, and this is in terms of radians. Now, you don't have to write this out, but for clarity, I'm just going to put RAD, which is the abbreviation for radians. But again, in the future, we're not going to write out radians. If we don't see something in terms of degrees, we'll just assume it's in radians. So the relationship here is that 180 degrees is equal to pi radians. And if I want to convert into degrees, well, what I want to do is I want to take the units that I don't want and put them in the denominator. So I don't want radians, so I'm just going to put pi radians in the denominator, take the units you do want, put them in the numerator. So this is 180 degrees. And so I'm going to cancel this with this. So now the radians are gone. I'm going to have this in terms of degrees. And then I'm going to cancel this pi with this pi. So that's gone. 180 divided by 9 is 20. So basically you have 20 times 7, which is 140. And this is in terms of degrees. So this would be 140 degrees. So looking through the answers, we're going to want to select that one. So the 7 pi over 9 in terms of radians is going to be equal to 140 degrees. Okay, let's take a look at question 2. So we want to convert each radian measure into degrees. So here we have 3 pi over 4. And again, this is in terms of radians. And I'm going to multiply by, again, 180 degrees is equal to pi radians. So I don't want radians, so I'm going to put pi radians in the denominator. I do want degrees, so I'm going to put 180 degrees in the numerator. I'm going to cancel this with this, so that now we're in terms of degrees. I'm going to cancel this pi with this pi, so that's gone. 180 divided by 4, that's going to give me 45. So let me cancel this out and put 45. And then 45 times 3, that's going to give me 135. So this would be 135 degrees. So let's look for that right here. This is 135 degrees. 3 pi over 4 radians is 135 degrees. Okay, for question 3, again, we are asked to convert each radian measure into degrees. So here we have negative 5 pi over 3. And we'll just say that, again, 180 degrees is equal to pi radians. So I'll say this is in terms of radians, and I'll multiply this by, again, put pi radians in the denominator, since you want to get rid of radians. Put 180 degrees in the numerator, since you want to keep degrees. These units will cancel. And so what I'm going to have is 180 divided by 3. That's going to be 60. Pi over pi is going to be 1. So you have 60 times negative 5, which is going to be negative 300. And this is in terms of degrees. So this is negative 300 degrees. So looking through my answers, I want this one right here. So you can say that negative 5 pi over 3 in terms of radians is going to be equal to negative 300 degrees. Okay, let's take a look at question 4. So now we're asked to convert each degree measure into radians. So we're going from degrees to radians now. We use the same relationship. So 180 degrees is equal to pi radians. But now we're going to put pi radians in the numerator and 180 degrees in the denominator. If you're having trouble with this, always remember you put the units that you don't want in the denominator. So if I have negative 240 degrees, I multiply this by, I put my 180 degrees in the denominator, and I put my pi radians in the numerator. And again, the units you don't want are going to cancel away. And if you think about this right here, let me write this off to the side. So negative 240 over 180. Well, immediately you could remove a common factor of 10 because each number ends in a 0. So for negative 24, let me just write negative 1 here, times for 24, let me write that as 8 times 3. So 2 cubed times 3. For 18, let's go ahead and say that that's 9 times 2, or you could say 2 times 3 squared. What can we cancel? Well, one factor of 2 between the numerator and denominator, and one factor of 3 between the numerator and denominator. So that gives me basically negative 1 times 2 squared, and the way I wrote this was a little bit awkward. So let me put the 3 here and cancel that and put the 2 there so that's more clear. So negative 1 times 2 squared is basically 2 squared is done first, that's 4, and you want the negative of that, so that's negative 4. So let me put a negative out in front, and then I'll put a 4 here. Don't forget about this pi here. A lot of times we do this scratch work and we forget about it. So negative 4 pi, and this would be over. You're going to have basically down here just a 3, right? So I'll put this over here. You can write this out in front if you want to make it a little bit cleaner. So this is negative 4 pi over 3, and this is going to be in terms of radians. Let me scooch this down so it fits. This will be RAD for the abbreviation. Again, in the future, you don't have to write that, but for clarity, right now I just write it. So what we're looking for, negative 240 degrees, that's going to convert over in terms of radians to negative 4 pi over 3. Okay, let's take a look at question number 5. So here we want to convert each degree measure into radians. So we have negative 330 degrees, so negative 330 degrees. And again, we have 180 degrees is equal to pi radians. So I don't want degrees, so I'm going to put that 180 degrees in the denominator, and I'm going to put pi radians in my numerator. And so these units here are going to cancel. And again, I'll put negative 330 over 180 and think about that off to the side. Again, you can immediately cancel a common factor of 10 because each number ends in a 0. I know that, forget about the fact that's negative. Let me just write negative 1 here. Times 33 is 3 times 11, so 3 times 11. And for this one, I'll just write it as 3 times 6. You're not really going to benefit from breaking that down any further. So let me cancel this with this. And so we'll say this is equal to, you have negative 11. Again, don't forget about this pi. It's really easy to forget if you do scratch work. So negative 11 pi, and this would be over your 6 there. So negative 11 pi over 6. This is in terms of radians. So let's look through. We have negative 330 degrees. In terms of radians, it would be this guy right here, which is negative 11 pi over 6. All right, let's take a look at our quiz. For the first question, we're asked to find the length of each arc. And so what we have here is a radius that is 15 miles. And we have a theta, which is given to us in radians, which is 7 pi over 6. Okay, so we're just going to use our formula. So S, the arc length, is going to be equal to R, the radius, which is 15 miles, times your theta, which is 7 pi over 6. You have a common factor of 3 between 15 and 6. 15 divided by 3 would be 5. 6 divided by 3 would be 2. So this ends up being 5 times 7, which is 35. So 35 pi over 2. Now, don't forget about your units. You have these miles here. So let me put that there. And then the ending answer here for the length of the arc, it's going to be 35 pi over 2 miles. Okay, for question 2, we want to again find the length of each arc. And so here we have a radius, which is 12 kilometers. And we have a theta, which is 3 pi over 4. And again, I'm just going to say that as the arc length is going to be 12 kilometers times 3 pi over 4. We know that 12 divided by 4 would be 3. So this is 3 times 3, which is 9, times pi, and this is in terms of kilometers. So I'm looking for 9 pi kilometers, so that guy right there. Okay, for question 3, we're asked to find the length of each arc. Here the radius is 5 yards, and theta is 90 degrees. So you need to convert this over if you're going to use that formula. So if we say S is equal to R times theta, theta has to be given in radians. But for 90 degrees, a lot of you know that's pi over 2 radians. You can also just convert it over by saying this is times your pi radians over 180 degrees. we have 90 degrees over 180 degrees. That would be a half. So basically this becomes pi over 2 radians, okay? So to plug into the formula, you would just say this equals pi over 2. And so you could say as your arc length is equal to, your r here is 5 yards, then times your theta here is pi over 2. And so this is just going to be 5 pi over 2 yards. So this is the answer I want, so 5 pi over 2 yards. Okay, let's take a look at question 4. So now we want to find the area of each sector. And so this is a different formula. We have the area is equal to 1/2 times your radius squared times your theta. Now, theta has to be given again in radians. Here we have that the radius is 9 kilometers and theta is 225 degrees. So I need to convert this over. So 225 degrees times pi over 180 degrees. Just think about 225 over 180. Well, 225 is 15 squared. And for 15, it's 5 times 3. So really, this is 3 squared times 5 squared. For 180, it's 18 times 10. So let me first start with 18 times 10. And 10 is 5 times 2, so 5 times 2. 18 is 9 times 2. So this is 3 squared, and then let me put 2 squared over here. So basically 2 squared times 3 squared times 5. Now, what can I cancel? Well, one of these 5s here with this guy right here, and then this would cancel. So basically you're left with 5 over 2 squared or 5 over 4. So this would end up being 5 pi over 4 in terms of radians. Okay, so let me write that over here. So this is 5 pi over 4. And then we can just plug into the formula now that we have that. So the area is equal to 1/2 times, for your radius, it's 9 kilometers, and it's going to be squared. Don't forget to square the units there. And then times your theta in radians, so this is 5 pi over 4. So this is 1/2 times 9 squared is 81. And you have kilometers squared. Let me move that out to the right. And then 5 pi over 4, we're going to multiply by that. Now, 81 is 3 to the 4th power. So you really can't do anything to cancel here because this is the 2 and this is 4, which is 2 squared. So you just multiply 81 times 5, which is going to be 405. And then basically, let me make this 5 better here. You're going to multiply by pi, and this would be over 2 times 4, which would be 8. And this is in terms of kilometers squared. So we're looking for 405 pi over 8 kilometers squared. Okay, let's look at question 5. Again, we want to find the area of each sector. So let me convert this over. We have a radius of 14 inches and theta, which is 315 degrees. So we're going to go 315 degrees times pi over 180 degrees. So let me think about 315 over 180. So I know 180, I just factored it, is 2 squared times 3 squared times 5. But what about 315? Well, you could start by dividing it by 5, and you would get 63 times 5. Let me put 5 times 63 like this. And 63 is going to be 9 times 7, or you could say 3 squared times 7 like this. And so you can see that you can cancel this 9 with this 9, this 5 with this 5. So you're going to get 7 over 4. So this is going to end up being 7 pi over 4. So this equals 7 pi over 4. Let me write that right there so we have it. We'll get rid of this, and now we can use our formula. So we'll say that our area is equal to 1/2 times your radius squared, so 14 inches squared, times your theta, which is 7 pi over 4. So you're going to have 1/2 times 14 squared is 196. And then you're going to have your square inches. Let me put that down there, or inches squared, however you want to say that. Then times 7 pi over 4 like this. So if we divide 196 by 4, you're going to get 49. So basically you would have 49 times 7, which is 343. So this is 343 pi over 2, and this is square inches. So I'm looking for this answer right here. So 343 pi over 2 square inches, or inches squared. All right, let's take a look at our quiz. So for question 1, we're asked to use the unit circle to find the exact value of each trigonometric function. And we're given the secant of 7 pi over 6. So when we think about 7 pi over 6, that's going to be right here on the unit circle. And when you think about the secant, it's going to be the reciprocal of your cosine. So the cosine value is the x value for this point. So let me write that the cosine of 7 pi over 6 is equal to the negative of the square root of 3 over 2. And if I think about the secant, so the secant of 7 pi over 6, Well, it's going to be the reciprocal of this guy. So you could say it's negative 2 over the square root of 3. And I'll just rationalize the denominator. So I'll multiply by the square root of 3 over the square root of 3. So that's going to give me the negative of 2 times square root of 3 over 3. So let's come down here and look for the negative of 2 times square root of 3 over 3. So that's what I want. Okay, let's look at question 2. So again, we want to use the unit circle to find the exact value of each trigonometric function. And here we have the tangent of 11 pi over 6. So here's our 11 pi over 6. And with the tangent function, we know that for this 11 pi over 6, this is equal to your sine of 11 pi over 6 divided by your cosine of 11 pi over 6. So this is what? The sine value is the y coordinate here. So we would say that this is negative 1/2. And I'm going to multiply by the reciprocal of the cosine value, which is the x coordinate here. So 2 over the square root of 3. Okay, so again, I'm dividing here, but I sped up the process. I'm just multiplying by the reciprocal. If you want to do it the longer way, that's really up to you. Okay, I'm going to cancel this with this and say this is negative 1 over the square root of 3, and then multiply this by the square root of 3 over the square root of 3, so I can rationalize my denominator. So this gives me the negative of the square root of 3 over 3. So coming down here, I want the negative of the square root of 3 over 3, so that guy right there. Okay, for question 3, once again, we're asked to use the unit circle to find the exact value of each trigonometric function. And here we have the cotangent. So the cotangent of 9 pi over 2. So if you're ever confused about whether this guy is greater than 2 pi, just look at the denominator. So it's in terms of 2, right? So I can say that if I had 2 pi and I multiplied it by 2 over 2, that would be 4 pi over 2. Now, if I look at 9 pi over 2, that is clearly greater than 4 pi over 2. So what I would want to do here is find the coterminal angle, and I'm going to need to actually subtract away more than 4 pi over 2, because if you think about it, 9 minus 4 would give me 5, so I would have 5 pi over 2, which is still greater than 4 pi over 2, so it's still greater than 2 pi. So I'm going to subtract away 4 pi here. I'll say that 9 pi over 2 minus 4 pi, which if I multiply by 2 over 2, I'm going to get 8 pi over 2. So this gives me pi over 2, and pi over 2 is going to be right here. Okay, so now I got that. So let me put that this is equal to your cotangent of pi over 2. Now, for the cotangent, it's going to be your cosine of pi over 2 over your sine of pi over 2. And so this would be equal to, for the cosine of pi over 2, it's the x-coordinate, which is 0. And then for the sine of pi over 2, it's the y-coordinate, which is 1. 0 over 1 is just 0. So coming down here, this is going to be 0 for the answer. All right, let's take a look at question 4. So we want to use the unit circle to find the exact value of each trigonometric function. And here we're going to work with the sine of 17 pi over 4. So clearly that's larger than 2 pi. If you think about 2 pi and you multiply it by 4 over 4, you get 8 pi over 4. So if you're ever lost, you could just think about it like this. Just get a common denominator and then compare. So this guy is clearly bigger than this guy. Now, in order to get a coterminal angle, I would need to subtract away more than 8 pi over 4, because 17 minus 8 is going to be 9, and 9 pi over 4 is still greater than 8 pi over 4, so that wouldn't quite work. So you need to do 17 pi over 4 minus 4 pi, which is basically times 4 over 4 to get a common denominator. So I'm subtracting away 16 pi over 4. And so this would give me pi over 4. So let me say this is equal to the sine of pi over 4. So the sine of pi over 4. Let's go to the unit circle. We see that's right here. And so you want your y-coordinate from that point right there. And that is the square root. Let me make that better. So the square root of 2 over 2. So coming down here, I want this one. So the square root of 2 over 2. Okay, for question 5, again, we want to use the unit circle to find the exact value of each trigonometric function. And here we have the secant of 15 pi over 4. So the secant of 15, let me make that better. So 15 pi over 4. So first and foremost, let me get a coterminal angle. So we'll do 2 pi, and I'll multiply by 4 over 4. So this would give me 8 pi over 4. And if I subtracted 15 pi minus 8 pi, that's going to give me 7 pi, and it's over 4. So 7 pi over 4 is going to be less than 8 pi over 4. So that's all we would need to do. So let me subtract 15 pi over 4 minus 8 pi over 4. And we know that this is going to give me 7 pi over 4. So we'll say this is equal to the secant of 7 pi over 4. So the secant of 7 pi over 4, which is equal to 1 over the cosine of 7 pi over 4. So where is 7 pi over 4? That's going to be right there. And the cosine is going to be the x value of that point. So it's square root of 2 over 2. So this is 1 over the square root of 2 over 2. So I'm just finding the reciprocal of that. So let's say this is equal to 2 over the square root of 2. And I'll multiply by the square root of 2 over the square root of 2 to rationalize the denominator. So this becomes 2 times square root of 2 over 2. And we'll cancel a common factor of 2 between numerator and denominator. So this ends up giving me a final answer of the square root of 2. Right, so for my secant of 15 pi over 4. So coming down here, we want to select the square root of 2. All right, let's take a look at the quiz. For the first question, we're asked to solve each word problem. We have that Beth needs to cut the grass. To get the engine to turn over, the pulley must turn at 10,800 revolutions per hour. The pulley has radius of 2.4 inches. What is the needed angular speed of the pulley in radians per second? And then how fast does Beth need to pull the cord in order to start the lawnmower? So we're trying to figure out two things. One is the angular speed, so that's pretty obvious. Let me put omega in here for that. And remember, this is theta, your angle measure in radians, over t, your time. The other guy we were trying to find is linear speed, so that's v. And this is going to be your omega, which is this guy right here, times your radius. Now, this might not be obvious from reading the problem because you might be thinking about, well, they're pulling a cord. But remember, if you're pulling a cord and that cord is moving along the pulley, well, what you can say is that the linear speed of the cord is going to be the same as that of a point on the circumference of that pulley. Okay, so we can use the same strategy here for that. Okay, so let's just start with the angular speed. It's pretty easy to get. So we have this right here that says 10,800 revolutions per hour. Okay, so in one revolution, you're generating an angle of 2 pi, right? It's one complete rotation or one circle, however you want to think about that. And you have 10,800 of those. So let's say that we have 2 pi times 10,800. Now, I'm not going to simplify that just yet. I'm going to put my units of time down here. So I'm going to put this in terms of 1 hour. So 1 hour. Now, if we look through the answers, we see that we're going to want things in terms of seconds. So I'm just going to do a simple little unit conversion here. And we already know that 1 hour is equal to 3,600 seconds. If you don't know that, then again, 1 hour is equal to 60 minutes, and then 1 minute is equal to 60 seconds. So basically, you could multiply 60 times 60, and you would have 3,600 seconds is equal to 1 hour. So let me put this up here as 1 hour. Let me put this down here as 3,600 seconds. Okay, so I'm just going to cancel the units away here. And you could divide this on your calculator, 10,800 divided by 3,600, and that's going to give you exactly 3. So let me cross these out and put a 3 here. So really, I'm going to end up with 6 pi radians per second. So let me get rid of this, and I will write this as 6 pi radians per 1 second. Of course, you could write it like this, so 6 pi radians per second. Okay, so now for the linear speed. You're going to take this guy, the angular speed, and multiply by the radius. So we have 6 pi over 1 second. Now my radius is given to me in inches, right? It says 2.4 inches. So 2.4 inches. Now here, again, when you look at this guy, all the answers are in terms of feet. So if you take 12 inches, that's going to be equal to 1 foot. Okay, so what I can do here is multiply this by, we'll put 1 foot up here, and then I'll put 12 inches down here. And so I'll cancel this with this, so those units are gone. And then we can just start dividing things. So 6 and 12, there's a common factor of 6. So let me get rid of this and cancel this away and put a 2. So basically, number-wise, you would just do 2.4 divided by 2, and that's going to give you 1.2. So this would end up being, we'll say v, our linear speed, is equal to 1.2 pi, and then you're going to have feet, and this is per second. Okay, let me get rid of this. I think this is a little bit more clean, so I'll drag this up here. So our angular speed is 6 pi radians per second, so that's going to be right here. And then our linear speed is going to be 1.2 pi feet per second. So this is the answer we want. Okay, let's take a look at question 2. So again, we want to solve each word problem. We have a windmill blade with a 30-inch diameter makes 7,200 revolutions per hour. What is the linear speed in inches per second of the windmill blade? Okay, so if we want the linear speed, again, V is equal to your omega, your angular speed, times your radius. So let's find the angular speed first. So this is going to be theta over the time. So theta here, you have 7,200 revolutions per hour. So again, all you do is you say 1 revolution is 2 pi, and I have 7,200 of them. And this is in terms of 1 hour. Now, it is asking us for inches per second. So again, I need to do a little unit conversion. And I'm going to multiply this by 1 hour over 3,600 seconds. So let's cancel these units away. And if I think about 7,200 divided by 3,600, that's exactly 2. So let me cancel this away, cancel this, and this is 2. So this would end up being 4 pi radians per second. I'm actually going to erase all of this and write this more neatly. So let's write 4 pi over 1 second. And then you could also write it as 4 pi radians per second like that. Now the next part of this is to figure out the linear speed. So that's the V is equal to this guy right here. So the 4 pi over 1 second times your radius. The radius, here you have a 30-inch diameter. Now, with the radius, it's half of the diameter, so it's going to be 15 inches. And we want this in terms of inches per second, so really all we have to do is multiply. 4 times 15 is 60, so this would end up giving me 60 pi inches per 1 second. Okay, or you could say 60 pi inches per second. So just looking through the answers, I want this one right here. V, my linear speed, is equal to 60 pi inches per second. All right, let's look at question 3. And I think because of the image in here, it's making it a little bit hard to read. So I'm just going to read this for you. Hopefully you're on this question and you can read the text. So we want to solve each word problem. So a toy drone has blades that rotate 5,400 times per minute. If the length of each blade is 14 centimeters, what is the linear speed in centimeters per second? Note, see the image below for a representation of a drone blade. The reason I put this in is because a lot of different drones will have a blade that looks like this, but some of them have a propeller blade, right? So it would be different based on the type of blade you get. So I want to make it crystal clear that the diameter of this blade, or from right here to right here all the way through, that's 14 centimeters. So what you're going to end up wanting is from right here to right here, which is half that. So your radius, I'm just going to put R here, is 7 centimeters. Okay, so based on this, to get the linear speed, again, you could just start with the angular speed. So omega is equal to your theta. In this case, you have 5,400 times per minute. So 2 pi times 5,400. And then this is over 1 minute. Now we want things in terms of seconds. So let me multiply this by. We know that in 1 minute, there's 60 seconds. Let me put 1 minute up here. Let me put 60 seconds down here. And then I'm just going to cancel these unwanted units away of minutes. So that's gone. 5,400 divided by 60, that's going to be 90. So let me cancel that away and put 90. So this would be 180 pi, and this is radians per second. So let me get rid of this. I'll just write this more neatly, and I'll say this is 180 pi over 1 second, or of course you could write it as 180 pi per second. Okay, so now we're asked for the linear speed v. So let's multiply 180 pi times this 7 centimeters over 1 second. So 180 times 7, that's 1,260. So we'll go ahead and say this is 1,260 pi centimeters per second. So this is going to be for my V. So looking through the answers, we want this one. So V, the linear speed, is equal to 1,260 pi centimeters per second. All right, let's take a look at question 4. So we want to solve each word problem. So we have a carousel at the school fair makes 180 revolutions per hour. Bob is riding a horse that is 270 inches from the center. What is Bob's linear speed in feet per second? So I think this one's pretty obvious, but let's say this is the center and you have a carousel. And let's just say that this circle here, which is a poorly drawn circle, but this circle, let's say that Bob's horse is somewhere, let's say right there. And the distance from the center to where that horse is 270 inches. Okay, so we're going to use that as our radius. Let me just get rid of this terrible picture here. And we'll say that the radius is 270 inches. And then basically we need our angular speed. So let me set up this omega, and that's going to be theta over t. Well, the time here, this is given to us in terms of per hour. So let me put 1 hour. And then it's 180 revolutions. Each revolution is 2 pi in terms of the radians. So 2 pi times 180, let's just put 360 pi. Okay, so what we would do is multiply this times this. But we want this in terms of feet per second. So you have to do 2 conversions here. So first I'll put this into seconds. So let me multiply this by 1 hour over, we'll go 3,600 seconds. And let me cancel the unwanted units away. So we know that 360 and 3,600, well, they have a common factor of 360. I could divide 3,600 by 360 and I would get 10. So you can cancel this with this and put a 10 down here and a 1 up here if you want. And so your omega would end up being pi radians per 10 seconds, right? Or you could write it another way. You could really say it's pi over 10. So pi over 10. So that's about 0.314. So that many radians per second. Okay, I'm going to keep it like this just for us multiplying in a second. You're going to see that that 10 is going to cancel away anyway, so it doesn't matter. Let me move this up here. And so if I want my linear speed, so v, this is equal to my angular speed, which is pi radians. Let me get rid of the radians. We don't need that right now. Over the 10 seconds here. And then times, we have this radius, which is 270 inches. Now I need to convert this over into feet. So I'm going to put 1 foot up here. And this will be over, I'm going to put 12 inches down here. The units I don't want are going to cancel. So let me cancel that away. You can divide 270 by 10. So let me cancel that away and put 1. I'm going to cancel 1 0 away there. So basically what you're left with is 27 over 12. Now each guy there is divisible by 3. If you divide 27 by 3, you get 9. So let me cancel that away and put 9. If you divide 12 by 3, you get 4. So 9 over 4, or you could say 2.25 if you wanted to do that as a decimal. So let me say that my linear speed is equal to, we're going to say 2.25 pi feet per second. Okay, let me get rid of this. It's a bit messy. I think nobody can really even read that at this point. So let's move this up here. So this is what we're looking for the answer. So 2.25 pi feet per second. Okay, let's take a look at question 5. So we want to solve each word problem. So at a local sewing factory, thread is being pulled off of a spool at a rate of 2.1384 kilometers per hour. We want to find the radius of the spool in centimeters if it makes 152 revolutions per minute. Round your answer to the nearest hundredth. Okay, this one is a bit tricky, but I want you to remember all your different formulas. So first off, you have that v, your linear speed, is equal to your s, your arc length, divided by your t, which is your time. Then you have your omega, which is equal to your angle theta, divided by your time. You could also write this as basically r, the radius, times your omega. Okay, so you could, as one strategy, plug in for v and plug in for omega. We have enough information to figure that out, and then solve for r, the radius. You could do it that way. You could also use this formula because we know that s, the arc length, is equal to r multiplied by theta. Well, you could divide both sides by theta, and you could say that your r, your radius, is equal to your arc length divided by your angle theta. So lots of different options. I think this one's probably the quickest. So let's go ahead and see if we can set everything up. Okay, so I'm just going to start with the fact that they are giving me my linear speed. It says right here that thread is being pulled off of a spool at the rate of 2.1384 kilometers per hour. But keep in mind that down here, when you look at your angular speed, this is in revolutions per minute. Okay, so we're going to need to transform this over. Either this guy's got to be in minutes and this guy's got to be in minutes, or they both have to be in hours. You got to make a match. Okay, so what I'm going to do is start off with what they give me. So 2.1384. So this is kilometers per 1 hour. Also, we need this in terms of centimeters, so I didn't even think about that. So to get this in terms of centimeters, you would need to move the decimal point 5 places to the right if you consult a prefix chart. So let's say that this is actually going to be, I'm going to put 2, 1, 3, 8, 4, and then 0. So I'm moving this 1, 2, 3, 4, 5 places to the right. So this is centimeters per 1 hour. Let me actually erase this. So we did one conversion. So now this needs to be in terms of minutes. And in an hour, there's going to be 60 minutes. So let me put 1 hour up here. And let me put 60 minutes down here. So let's do this on our calculator. We're going to type in 213,840 divided by 60, and that's going to give us 3,564. So let's say that v, the linear speed, is 3,564. This is centimeters, and this is going to be per 1 minute. So let me get rid of this, and we have this. So this is our linear speed. Now let's bring this up here. So for the angular speed, this guy right here is going to be coming from, you have your omega, and this is equal to, again, 152 revolutions per minute. Well, each revolution, that's an angle of 2 pi, right? So you have 152 of those. So you multiply 152 times 2 pi, and that's going to give me 304 pi. So 304 pi, and this is in terms of radians per minute. Now, you can see that if you multiplied this right here by the radius, you would get this right here, okay? So that's why these time units have to match up, okay? And then the radius would have to be in terms of centimeters. So basically, this times some unknown radius would give me this. So you could solve it that way. I think maybe we'll just do it that way. It's a little bit more time consuming, but we've already set this up. So let's say that v is equal to r times omega, like this. And so I'm just going to plug in for v. So this is 3,564 centimeters per 1 minute. And this is equal to your r, which is unknown, times your omega, which is 304 pi over 1 minute. So what would I do? I could just cross multiply here, and I could multiply by 1 minute over 304 pi like this. Let me come down here. And you would end up saying that this is going to cancel. And let me show this over here and slide this down so it fits. So we'll put this 1 minute over 304 pi. And then I'm going to show this canceling here. So basically what you're doing is you're going to have 3,564 centimeters divided by 304 pi. And that's what we would expect for a radius. We wouldn't have a time unit with radius. That wouldn't make any sense. So this guy right here, let's just punch that into the calculator. 3,564 divided by 304 pi. So let's say the radius is approximately, I'll say 3.73, and this is in terms of centimeters. Now, before we go up and circle our answer, I just want you to note that basically if you had done it the other way, where you said that r is equal to s, the arc length, divided by theta, it's the same thing, right? 3,564 centimeters, that's the arc length here in terms of centimeters. Then 304 pi, that is your theta in terms of radians. So you basically did the same thing. It's just a little bit longer when you set up this equation this way, but it's up to you what you want to do. So this is going to be our answer. The radius is approximately 3.73 centimeters. Let me erase this. So I'll come up here and circle this one. So the radius r is approximately 3.73 centimeters. All right, let's take a look at the section quiz. For the first question, we're asked to convert each radian measure into degrees. So we have negative 10 pi over 3. So this is in terms of radians. So to convert this into degrees, I want you to recall that 180 degrees is equal to pi radians. Now, typically when we work with radians, we don't write out radians. It's unnecessary. But for right now, since we're doing a little unit conversion, we'll write it out. So I'm going to multiply this by, always put the units you don't want in the denominator. So I'm going to put pi radians down here. The units I do want, that's going to go in the numerator. And so in this case, let's cancel this with this. So that's going to be gone. Let's cancel this pi with this pi. So that's gone. And essentially what I'm going to do, let me get rid of this so we have some room. I am going to cancel 180 divided by 3 would be 60. So let's just say this is 60 degrees here times negative 10, which would be negative 600 degrees. Okay, so looking through my answers, I want negative 600 degrees. Okay, let's look at question 2 now. So now we want to convert each degree measure into radians. So we have negative 60 degrees. And again, I'll just write out that 180 degrees is equal to pi radians. So you're going to multiply this by, again, the guy you don't want, put that in the denominator. So I'm going to put 180 degrees down here. And the guy I do want, put that in the numerator. So pi radians. Okay, so we can see that degrees would cancel. And then 180 divided by 60 is going to be 3. So let's go ahead and say this is 3 down here. And let me write this as negative 1 here. So basically you would have negative 1 times pi over 3 radians. Let me get rid of this. And I'll just write that we have negative pi over 3. And this is in terms of radians. So let's select this answer here. So negative pi over 3 radians. All right, let's take a look at question 3 now. So we want to find the length of each arc, and we're given a radius r of 13 yards and a theta that's equal to 270 degrees. So the formula for arc length, it's denoted with s, and this equals r, which is your radius, times theta, but theta has to be given in radians. Okay, if it's not, you have to convert it, or you have to use a different formula that we talked about before. So for this guy, theta equals 270 degrees. So let's just convert this over to radians. Actually, instead of putting equals, let me just multiply this by. Again, 180 degrees is equal to pi radians. So let me put pi radians up top. Let me put 180 degrees on the bottom. So basically, the degree unit is going to cancel away, and you're just thinking about 270 divided by 180. Of course, you could immediately cancel a common factor of 10, and then with 27 and 18, there's a common factor of 9. So 27 divided by 9 is 3, and 18 divided by 9 is 2. So this would be 3 pi over 2 radians. Let me get rid of this, and you can just get rid of this. And I'll say this equals 3 pi over 2. That's in terms of radians. So now you just plug in and multiply. So all I would do is say that as the arc length is equal to, you have 13 yards times 3 pi over 2. And we know that 13 times 3 is 39. So this is 39 pi. And then we'll say over 2 yards. Now, you could approximate this with your calculator, but you see that the answers we're given are not approximated. So I'm just going to circle this one and say it's 39 pi over 2 yards. All right, let's take a look at question 4 now. So we're asked to find the area of each sector. So here we're given a radius r, which is equal to 8 miles, and we're given a theta, which is 3 pi over 4. So for the formula, it's going to be area is equal to 1/2 times your radius squared times your angle theta, and theta has to be given in radians. So here it's in radians, so we're good to go. So we're just going to plug in. So the area is equal to 1/2 times, for the radius, it's 8 miles, and you've got to make sure that you square the miles, right? So you want to end up with square miles. Then times your theta, which is 3 pi over 4. So let's just say that this is 1/2 times 8 squared is going to be 64. And then let's say times 3 pi over 4. Let me write the miles squared over here on the end. And basically, if you look at this, 2 times 4 would give you 8. So you can cancel 64 with 8, and that would give you 8 up here. So if you multiply through, 8 times 3 would be 24. So this would be 24 pi miles squared, or you could say square miles if you wanted to, whatever you want to do. But this is the answer you want. So you want 24 pi square miles or miles squared. Okay, for question 5, we have a circular sector has an area of 50 square inches. The radius of the circle is 5 inches. What is the arc length of the sector? So this is sort of the last question in reverse. Now we're actually given the area. So let's just write that formula out again. So the area is equal to 1/2 times the radius squared times your angle theta. So we're just going to plug in for what we know, and we're going to end up having to solve for theta. And then we'll plug back into the s is equal to r times theta. Okay, that's for the arc length. So what we'll do here is say that the area is 50 square inches. You could write inches squared like that, or you could write out square inches, whatever you want to do. This is equal to 1/2 times your radius squared. So the radius, it tells us, is 5 inches. So if I square the 5, I get 25. And if I square inches, I get inches squared, right? So that's just me putting 5 inches like that and squaring it. 5 squared is 25. Inches squared is square inches or inches squared, whatever you want to say. Then it's times theta. Okay, let me get rid of this. We'll bring this back in a second. And actually, let me get rid of this. So the unknown here is theta. So that's what I'm going to solve for. And I think it's probably easier if I just write this as over 2 like this, just so it's nice and convenient. And I'm just going to multiply this by the reciprocal. So 2 over 25 inches squared. And if I did this over here, so 2 over 25 inches squared, well, this right here is just going to cancel out, right? It'll just be 1. So you could say that theta is going to be equal to 50 divided by 25 is 2 inches squared over inches squared. That's going to cancel away. So you basically have 2 times 2, which is 4. Okay, so this is going to be 4 for my angle theta in radians. So let's say theta is equal to 4. And then, of course, we know r, the radius, is 5 inches. So if I want s, my arc length, well, basically it's just r times theta. So 4 times 5 inches would be 20 inches. So I'm just going to select this answer right here for 20 inches. All right, let's take a look at question 6. So here we have that a tractor windshield wiper, 10 inches long, rotates through an angle of 60 degrees. If the rubber part of the blade covers only the last 9 inches of the wiper, find the area of the windshield cleaned by the windshield wiper. So this is one where I recommend making a little picture. You know that the windshield wiper is 10 inches long, but only the last 9 inches is going to have that rubber part that cleans the windshield. So looking at this guy, again, this total length is 10 inches, but from right here to right here, and I know this is not perfectly drawn to scale, but from right here to right here, let's just say that's 9 inches. So that's the part that has that rubber. So that's going to allow me to clean this part. Let me highlight that a little bit better. So this part right here of the windshield. So this that I'm highlighting right here, this is the part that's going to be cleaned, and we want to find that area, okay? This part right here is not going to be cleaned, right? So it's not going to be cleaned. Let me put that there. So not cleaned. So how can we figure this out using the area of a sector formula that we learned already? Well, what you could basically do is consider the fact that you can find the area of the whole thing, and then you can also find the area of the part that's not cleaned, and then you can just subtract. So I could just take the area of the whole thing, subtract away the area of the part that's not cleaned, and I'll have the area of the part that is cleaned. So let me actually get rid of this. I think we know what we're doing now. And I'll just write out my formula. So the area for a sector, so the whole thing here, that is going to be 1/2 times your radius squared times your angle theta. Now in this particular case, the angle theta is given in degrees. We saw earlier that 60 degrees was pi over 3 in terms of radians. So let me put pi over 3 there. Now the radius, you're just going to use the fact that for the whole thing, this is an inch and this is 9 inches. So this guy is going to be 10 inches, again, if I'm considering the whole thing, right? So I would put 10 inches, and of course you need to square that. So this would end up giving me an area for the whole guy of 1/2 times 10 squared is 100 times pi over 3, and then you would have inches squared out here. So this is 100 pi over 6 square inches. So 100 pi over 6 square inches, or inches squared, however you want to say that. So that's my total area. Maybe I'll notate that by saying TA for total area. So let me move this up here. Now, I'm not going to simplify this. A lot of you will say, well, that's 50 pi over 3. You're going to need a common denominator in a moment, so just leave it like that. You're going to end up double working. So then the not cleaned area, let me put NA for not cleaned area. This is going to be what? Well, this is only 1 inch for the radius. So basically what you're going to do is say this is 1/2 times for the radius. It's going to be 1 inch, and we're squaring that, and then times your same angle, which is pi over 3. And so an inch, if you square that, well, 1 squared is just 1. So you're just going to move the units out here and say this is inches squared. So this would be pi over 6 inches squared. So this is pi over 6 inches squared. So to get the area of the part that I want, again, this part right here, and I'll just notate that with a regular area, it's going to be this minus this. So 100 pi inches squared minus pi inches squared over the common denominator of 6. Let me get rid of these middle steps here. We don't need this information anymore. And basically, if I move this up here, 100 pi minus pi is 99 pi. So this would end up being 99 pi inches squared over 6. You can cancel a common factor of 3 between numerator and denominator. 99 divided by 3 would be 33. So this is 33. 6 divided by 3 would be 2. So this is 33 pi over 2, and this is inches squared, or you could say square inches. So coming back up here, if you want to find the area of the windshield cleaned by the windshield wiper, it's going to be 33 pi over 2 square inches, or you could say inches squared. All right, for question 7, we're asked to use the unit circle to find the exact value of each trigonometric function, and we're looking at cosine. Let me write this out because we have to go back there. So cosine of negative 25 pi over 6. Okay, so what I'm going to do is actually put this in terms of its coterminal angle. So I'm going to say negative 25 pi over 6. Just think about this in terms of the denominator. So if you thought about, let's say, 4 pi, well, if I did 4 pi times 6 over 6, that would be 24 pi over 6. So that's not enough to make this not negative. So you're going to have to add 6 pi, right? So anything that's a multiple of 2 pi, you're okay, right? You're just adding 360 degrees if you're converting back to degrees. 2 pi would be the same thing. So I'm going to add 6 pi, which if I multiply by 6 over 6, this would be 36 pi. So 36 pi over 6. So we have that common denominator there. So I just need to do negative 25 plus 36. That's going to give me 11. So this would be 11 pi over that common denominator of 6. So let me erase this and just say that this is equal to the cosine of 11 pi over 6. So that's my coterminal angle. And I'm just going to find that on the unit circle. So that's going to be right here. And you just want to take the x coordinate if you want your cosine value. So it's going to be square root of 3 over 2. So this is the square root of 3 over 2. And coming down here, I'm just going to select that it's the square root of 3 over 2. Okay, let's take a look at question 8. So here we want to use the unit circle to find the exact value of each trigonometric function. And coming down here, it's the cosecant of negative 35 pi over 6. So the cosecant of negative 35 pi, and this is over 6. So let's grab this, and I'm just going to paste this in here. And again, I'm just going to find my coterminal angle. Now, we just looked at a problem where we added 6 pi, right? 6 pi is 36 pi over 6 if you get a common denominator with that 6, and that's going to work out perfectly for us. You can do negative 35 pi over 6 plus 36 pi over 6. This is going to be 36 minus 35 is 1, so this should just be pi over 6. So I'm going to say that this is equal to the cosecant of this pi over 6. And what's that equal to? Remember, the cosecant is a reciprocal of sine. So I can say this is 1 over the sine of pi over 6. So this is 1 over, if I look at pi over 6, it's right here. And the sine of pi over 6, again, you want your y coordinate, it's 1/2. So 1 over 1/2, I'm just going to take the reciprocal of a half and get 2. So the final answer here for the cosecant of negative 35 pi over 6 is going to be 2. So coming down here, I just want to select 2. All right, let's take a look at question 9. So here we want to solve each word problem. We have that a Ferris wheel sits 10 feet above the ground and has radius 50 feet. A person takes a seat and then the wheel turns 2 pi over 3 radians. How far is the person from the ground? Okay, so this one is not that bad if you draw a picture. If you don't draw a picture, it's really hard to think about what's going on. So let's come down here to a little image that I've created. It's not perfect, but I think it'll do the job here. Now for a Ferris wheel, it moves in a circular path. And basically what's going to happen is it's going to come down here to, let's say, the bottom part. And you're going to have some mechanism. Usually the thing will lower or something like that, and you can get into it and then it'll come back up. Some of them don't work that way, but let's just say this one works that way. So after this thing lowers and you get in, this is the ground right here. You get in, it's going to come back to this point. So this is where you're sitting. Then we're going to rotate 2 pi over 3 radians, or 120 degrees if you want to put that in terms of degrees, to this point right here. So that's where you're sitting at when it's asking us how far or how high you are above the ground. Okay, so basically you want the distance from here going all the way down there to the ground. We know that this part right here is going to be 10 feet. Then we know, because of the radius of the circle, that from this point right here to this point right here, that's 50 feet. So that's 50 feet. So far we know this part to right here, let me change colors, to right here, that would be 60 feet. So you just need this part right here. Okay, let's just call it A. And you can quickly get that by just solving this right triangle that's formed. Okay, so you'd want the opposite here over the hypotenuse, because I know this angle is 30 degrees. So I could just say the sine of 30 degrees is going to be, let me put sine of 30 degrees. This is going to be A over your hypotenuse, which is 50 feet. Now, we already know from the unit circle that the sine of 30 degrees is a half. So you can actually just replace this with 1/2, and then you can multiply both sides by 50 feet. So you can say this is 50 feet times 1/2 is equal to A. And so if you just divide 50 by 2, you get 25. So you would say that A, or the length of this side right here that's opposite of this 30-degree angle, that's going to be 25 feet. So this right here would be 25 feet. So all we need to do to get from here to here is just add these guys up. It's 25 feet plus 50 feet, which is 75 feet, plus another 10 feet to get to the ground. So that's going to be 85 feet. So let's come back up here, and I'm just going to select how far is the person from the ground? Well, 85 feet. All right, let's take a look at question 10. So we want to solve each word problem. We have that the hour hand of a wall clock measures 6 inches from its tip to the center of the clock. What distance does the tip of the hour hand travel during the time period from 1 o'clock to 3 o'clock? So for this one, you might be used to just using your phone at this point, and maybe you don't know what a wall clock looks like anymore because you don't really see them that often. So I'll make a little image here that we can look at, and maybe I should probably make this a little bit bigger. Hopefully that doesn't pixelate too much. So the first thing is, here's the 1 o'clock and here's the 3 o'clock. So normally you're going this way, but let's just consider an angle that's rotating this way. So this is 60 degrees. And basically the way I got that was, this is split up into 12 segments there, okay? And so if you took 360 degrees, which would be the angle measure for one rotation, well, 1/12 of that, if I divided this by 12, I'm going to end up with 30 degrees, right? So what you would say is that from rotating from 3 to 2, that's 30 degrees, and then this would be 60 degrees, right? So basically 30 degrees times 2 is 60 degrees. That's how I got that angle measure there. Now, if we want the length of this right here, which is what we're trying to figure out, again, that's S is equal to R, the radius, times theta. So theta, all I have to do is convert that 60 degrees into radians, and 60 degrees, hopefully you know at this point, is pi over 3 radians, but you can also just do 60 degrees times pi radians over 180 degrees, and of course this would cancel with this and leave me with the 3 down there, so this is just pi over 3. Okay, so let me get rid of this, and I'm just going to put this as pi over 3. Now for the radius, it's going to be the length of that hour hand. So coming back up here, it says that that's going to be 6 inches from the tip, again, to the center of the clock. So that's your radius. That's what you're using. So let's come down here, and I'm just going to put this in as 6 inches. And of course, 6 divided by 3 would be 2. So S, the arc length there, is going to be 2 pi inches. So let me write that this is 2 pi inches. So coming back up, so what distance does the tip of the hour hand travel during the time period from 1 o'clock to 3 o'clock? It's going to be 2 pi inches. All right, let's take a look at question 11. So a race car travels at a constant speed around a circular track with a circumference of 4 miles. So remember, the circumference is the distance all the way around a circle. If the car completes 8 laps every 10 minutes, what is the linear speed of the car in miles per hour? And here we have hint, use the formula V, which is your linear speed, is equal to S, which is your arc length, so the distance that you're traveling around that circle, over T, which is your time. So this one's pretty easy. You're given the circumference, which is 4 miles. So if I go around the circular track once, that's 4 miles. Well, it tells me that he's doing 8 of those laps, so I need to multiply 8 times 4 and get 32. So this is 32 miles, over, we have a time period of 10 minutes. So this is 10 minutes. So this is my V right now, but the problem is I want this in terms of miles per hour, and right now I have miles per minute. So you just need to convert it over and say that there's going to be 60 minutes in every 1 hour. And so I'm going to cancel minutes with minutes. So that's gone. So let me actually cancel this 60 with this 10. 60 divided by 10 is 6. And so what you'd have is 6 times 32, which would give me 192. And this is in terms of miles per hour. So looking through my answers, I want this one. So it's 192 miles per hour. All right, let's take a look at question 12. So here we want to solve each word problem. We have that a bicycle wheel has a diameter of 78 centimeters. If the wheel revolves at a rate of 120 revolutions per minute, what is the linear velocity of the bike in kilometers per hour? So remember that we have our linear speed, which some books will call linear velocity. This is equal to S over T, right? S is the arc length. But you could also say that S is R times theta, right? So your radius times your angle theta measured in radians over your time T. And remember, you can take this omega, which is the angular speed, it's the theta over T part. And so you can break this up and say, well, this is just going to be the radius times your omega. Okay, so a lot of different ways to think about this. So what I'm going to do first is find this omega, or the angular speed. And so for this part right here, the angle theta, well, it tells me that it revolves at a rate of 120 revolutions per minute. Okay, well, each revolution or each complete rotation is an angle of 2 pi. Now you have 120 of those revolutions, so you just multiply those together, and you're going to get 240 pi. So this is 240 pi, and this is per 1 minute. Now we end up wanting this in terms of kilometers per hour, so you might as well just convert it over now and say that 60 minutes is equal to 1 hour. And so you can cancel the minutes away, and you would just have to do a multiplication here. 240 times 60, that's going to be 14,400. So let's say that omega is equal to 14,400 pi, and this is going to be in terms of radians per hour. So we'll just put this over 1 hour like this. Going to get rid of this, and we can get rid of this also. And I'm just going to drag this where it's out of the way, and we'll use it in a moment. Now, we want to find the linear velocity of the bike. So what we need to do is think about, again, that v is equal to the radius times this omega. Well, we have a diameter of 78 centimeters. So for the radius, it's going to be half the diameter. So 78 centimeters divided by 2. And so that's going to give me a radius that's 39 centimeters. Okay, let's think about what we can do now. We're going to multiply this 39 centimeters times this guy right here, this angular speed, which is 14,400 pi over 1 hour. Now, this is not in terms of kilometers, which is what we need. If you go to a metrics prefix chart, if you want to go from centimeters to kilometers, you're going to need to move your decimal point 5 places to the left. So let me erase this, and I'm just going to move this. Let me put 3 zeros in here. We'll need those. So 1, 2, 3, 4, 5. So this would be 0.00039 kilometers, or kilometers as some people say. So you're just going to do this multiplication real quick, and let me put v is equal to this. So let's punch this into the calculator. 0.00039 times 14,400, and I get 5.616. And of course, this would be pi, kilometers, and then per 1 hour. Let me erase everything. So v is equal to this. And of course, you could write this also as saying v is equal to 5.616 pi kilometers per hour like that. Or you can abbreviate it as kph, okay? Just like we do with miles per hour in the US, we go mph. So what we would do here is just circle this one. So we want 5.616 pi kilometers per hour, so kph. For right now, we're going to focus in this quiz on just getting the information out that we need. So basically, we have f of x equals a times the sine of, and this could be the cosine of, it's the same formula. You basically have this k times the quantity x minus b, and then plus d. So if we see something in this format, the amplitude is the absolute value of a. So this right here, just take the absolute value of it. And of course, a can't be 0. The period, as long as this k right here is positive, it's going to be 2 pi over k. If it's negative, you can either use identities to rewrite it, or you can just use absolute value bars around k. The phase shift is going to be b. And I have here specifically, it's right b units if b is greater than 0, and left by the absolute value of b units if b is less than 0. Again, that just goes back to what we've studied. If this was something like x plus 2, we're going to the left by 2 units. We're just saying that you could write that as x minus a negative 2. So basically, if this is less than 0, so this would be less than 0 here, we're going to the left by the absolute value of negative 2, which is 2. I know it's a little bit confusing when you see it like that, so I just go x plus 2, I'm going to the left by 2, and then if I have x minus 2, I'm going to the right by 2. That's really easy for me to remember. So then you have the vertical shift, that's just going to be d. We're going up by d units if d is positive, and we're going down by the absolute value of d units if d is negative. Okay, for the first question, and I don't know if you can see this, it's kind of small, it says find the amplitude, the period in radians, the phase shift in radians, and the vertical shift. So again, the first thing I do on these problems is just factor. So I say f of x is equal to 3, and then the sine of. What you want to do is pull this out, whatever the coefficient of x is. So pull that out. So I'm going to pull out a 5, and you have x plus. Just think about how I can undo that. So in other words, when I go through and multiply, 5 times what would give me 1? Well, it's 5 times a fifth. So just put a 1/5 there, and then times your 3 pi over 4. Again, I'll just check it on this first one. You can check them on the next one. Basically, if you do 5 times x, that's 5x, and then plus 5 times a fifth is 1, so then you have your 3 pi over 4. So you'd be right back to what you have. Let me make this 4 better. Looks kind of bad. So basically, if you want to go through and figure out, well, what's the amplitude? That's going to be the absolute value of 3. So the amplitude is 3. And then the period, so the period, that is going to be 2 pi, that's the standard period, divided by this 5 here. That's all it is. Then the phase shift, what we're thinking about, let me go through and put this together. This is 3 pi over 20. So 3 pi over 20. And again, if you want to use that formula, which I personally find confusing, you could write this as minus a negative. So that tells me I want to go to the left by 3 pi over 20. But the way that I like it is just keep it as a plus and say, how do I undo what's being done to x? I have x plus 3 pi over 20. To undo that, I need to subtract away 3 pi over 20. So that tells me I'm going to the left by 3 pi over 20. So left, 3 pi over 20. And then the vertical shift is easy. You have a plus 4 there, so the vertical shift is up 4. Okay, let's look through the answers. So all the amplitudes are the same, so that doesn't help us. Period is 2 pi over 5. That's right here, and then right here, and then right here. Then we have a phase shift left by 3 pi over 20, so that's going to be this one. This is what we want, and you see that it's up by 4 units. So everything there is a match. So we want this one, an amplitude of 3, a period of 2 pi over 5, a phase shift. We're going to go left by 3 pi over 20, and then going up by 4. All right, let's take a look at question 2 now. So again, we want to find the amplitude, the period in radians, the phase shift in radians, and then the vertical shift. So we have f of x equals 6 times the cosine of. We have this 8x plus pi over 3, and then we have plus 4. Again, I'm just going to factor this so we can use our little formula. So f of x is equal to 6, and then we have the cosine of. Let me go ahead and pull out this 8. So this 8 is out in front. And then you're going to have times the quantity. You'll have an x here and then plus. Again, if this is confusing for you, if you're pulling out an 8, just think about when I go to multiply it, how can I undo it? So in other words, 8 times what would give me 1? Well, it's going to be 1/8. So you put that there and then times your pi over 3. If you want to check that on your own, I'll leave that up to you. Close that down, and then this is plus 4. So this right here would end up simplifying to pi over 24. Let me erase this and say this is pi over 24. Okay, so now that we have this in this form, it's pretty easy to go through it. Let me slide down so we can see our answers here. Basically, what you want to do is start with the amplitude. So that's the easiest one. It's just the absolute value of this number right here. So that's just 6. Then the period, that's also pretty easy to get. You have 2 pi, which is your standard period for cosine or sine, divided by this right here. So 2 pi divided by 8, and you can simplify that. 2 divided by 2 is 1, and then 8 divided by 2 is 4, so it's pi over 4. Then you're going to have your phase shift. Again, this is the one that people struggle with. The way I do it, again, I just say, well, if it's x plus pi over 24, what do I need to do to undo what's being done to x? I need to subtract away pi over 24. So that means I'm going to the left by pi over 24. And then the vertical shift, that's pretty easy. You just have this plus 4 outside. So I'm just going to say we're going up by 4. All right, now in each answer, we have an amplitude of 6. So that really doesn't help us. When we get to the period, it's pi over 4. So you have that right here. And then you have that right here, and then right here. Then for the phase shift, you're looking for left by pi over 24. So this one says left by pi over 18, so that's out. This one says right by pi over 24, so that's out. And this one says left by pi over 24, so that's what you want. You do have the vertical shift up by 4, so this is the one that we want. All right, let's look at question 3. So we're asked to find the amplitude, the period in radians, the phase shift in radians, and then the vertical shift. Okay, let me slide down here a little bit. So again, I'm just going to factor. So f of x is equal to 1/2 and then times your sine of. I'm going to pull this out. This is x over 7. You could say that's 1/7 times x. So pull out 1/7. You can have x plus. Again, how do I undo multiplication by 1/7? Well, you could multiply by 7. 7 times 1/7 is 1. So just put a 7 there and then times your pi over 2. So that's 7 pi over 2. Again, I'll let you check that on your own. You'll see that it does work. Close that down, and then minus 3. Okay, so thinking about the amplitude, again, it's the absolute value of this number out in front, so it's just 1/2. For the period, it's just going to be 2 pi over this. Now, 2 pi divided by 1/7 is 2 pi times 7, so that's 14 pi. So it's a really large period, so 14 pi. Okay, then for the phase shift, I have plus 7 pi over 2, so I'm going to the left by 7 pi over 2. And then for the vertical shift, I'm just going down by 3 units because I have that minus 3 there. So let's see what we have for the choices. Amplitude 1/2, 1/2, 1/2, 1/2, 1/2. So everything has an amplitude of 1/2. The period is 14 pi, so that's right here and right here only. The phase shift, we want left by 7 pi over 2. So that's going to be right here. And basically, this is the one we want. So amplitude of 1/2, period of 14 pi. The phase shift, we're going left by 7 pi over 2. And then a vertical shift down by 3. All right, for question 4, again, we're asked to find the amplitude, the period in radians, the phase shift in radians, and the vertical shift. Okay, let's go. F of x is equal to, you have 3, and then times your sine of, let's pull out that 7. So times the quantity x minus, again, if I pull it out of 7, I'm going to put a 1/7 here, and then times 2 pi over 3. Let's just say that's 2 pi over 21 now. Get it over with. So 2 pi over 21, close that down, then minus 4. Okay, let me slide down here a little bit and just say that the amplitude is the absolute value of 3, which is 3. The period, let me just write P for that. It's going to be 2 pi over 7. The phase shift, we're going to be going, since this is minus 2 pi over 21, now we want right. We're going to the right. How do I undo this? I need to add 2 pi over 21, so I'm going to the right by 2 pi over 21. Okay, then we have the vertical shift. This is minus 4, so we're going down by 4 units. Okay, so amplitude is the same everywhere. Don't worry about that. The period, I have 2 pi over 7, so it's right there, and right there, and right there. And then I want to shift to the right. That's my phase shift by 2 pi over 21. So I'm going to have that right here only. Let me get rid of these. This is what I want. And I also have down by 4. So the amplitude is 3. The period is 2 pi over 7. The phase shift is right 2 pi over 21. And the vertical shift is down by 4 units. All right, let's take a look at question 5. So this one's a little bit different. It says find the transformation required to obtain the graph starting with the basic trig function y equals the sine of x. Okay, for this one, we're going to draw on our knowledge from graphing transformations from earlier in the course. If you see something like f of x is equal to a times the sine of, actually, let me use brackets here. I'm going to put this in factored form. So b times the quantity, let's just go x minus c. It doesn't really matter what letters you use, then plus d. What's important is to understand that when you see it in this form, this right here and this right here, these are vertical transformations. They affect y. This needs to be done first. This needs to be done second. So nobody's usually confused about that. That makes sense. This is first. This is second. Where people get confused is that in factored form, okay, let me say that again because a lot of people don't pay attention and they ask questions later on. So let me put this real clear. In factored form, okay, let me put that this right here is number 1 and this right here is number 2, okay, in terms of horizontal. So in other words, in factored form, let me highlight that once again, because if it's not in factored form, it doesn't work this way. But in factored form, you do your horizontal stretch or your horizontal compression first. Then you do your horizontal shift, what we call the phase shift. So this is 1 and this is 2 in factored form. So I've repeated that a bunch of times now. Hopefully everybody's paying attention and they know that this would not be the same if it's not in factored form. Now, let's match this up. Let me actually grab this real quick and bring this down here so we have a little model to follow. Now, just matching this up, what am I going to have? This is 1, this is 2 in terms of vertical. So you're going to have a vertical stretch by a factor of 4, and then you're going to have a shift up by 5 units. That's the order of the vertical. Then the order of the horizontal, again, this is done first, this is done second. When you think about how these things work in terms of on the inside, remember, it's the opposite of what you would expect. We are not going to say that we have a horizontal stretch by a factor of 7. You're getting a horizontal shrink. So basically what's happening is you have to think about all the x values are getting divided by 7 or multiplied by a 7th. So you're getting a horizontal compression. Depending on how you read it, a lot of books will say it's a shrink of a factor of 1/7, but a lot of books will also say a compression of a factor of 7. Whatever you want to do there, I'm just going to go with what the book says for this problem, and I'm going to go with a shrink by a factor of 1/7. And so this right here, this minus pi over 28, that creates a phase shift or a shift to the right by pi over 28 units. The way I'm going to read this is I'm going to go this one, this one, this one, then this one. So let me write this out. We're going to vertically stretch by a factor of 4. Then I'm going to say that we're going to, let's go compress. So vertically compress Or you could really say vertically shrink if you want. I'm going to use a factor of 1/7, but again, this just depends on the terminology you're using in your book. Some books will actually say, because you're a compression, they think about it as dividing by 7. So it'll say a vertical compression by a factor of 7, and then some will say a vertical shrink, maybe a vertical compression by a factor of 1/7. It's just semantics there, so don't worry too much about it. We're going to use 1/7 for this problem because that's what the book used. Then we're going to go through and we're going to say that we have a phase shift going to the right by pi over 28 units. So I'm going to go phase shift. We're going to go right. And then this is going to be pi over 28. And then the last one, we're going to go up. So this is your vertical shift. And this is going to be 5 units. Okay, let me grab all of this and paste this in. I'm going to come down here where you can read it, because it'd be hard to read. Let me move this here. So what am I looking for? A vertical stretch. So this says vertical stretch, and this says vertical stretch, and this says vertical stretch. So by a factor of 4. You have 4 and then 4. So get rid of this one. This one says 7. That's wrong. Then you have horizontally compress, and then you have shrink by a factor of 1/7. So that's consistent with this, and that's consistent with this. Then we have shift left by pi over 28, and this says shift right by pi over 28. So that's the one you want, and shift up by 5. So this is what you are looking for. You want to say that starting with the basic sine graph, you're going to vertically stretch by a factor of 4. Then you're going to horizontally compress, or you would say shrink, by a factor of 1/7. Again, depending on the book you're in, they might say horizontally compress by a factor of 7. It's just a matter of language. When they say compress, generally they mean, what are you dividing by? I'm dividing every x guy by 7. So you could say horizontally compress by a factor of 7. You could also say that you're multiplying by 1/7. So you could say that horizontally compress or shrink by a factor of 1/7. Don't get hung up on that. I know a lot of people do. Then you have a shift to the right by pi over 28. And then lastly, you have and shift up by 5. So this is what we want. All right, let's take a look at the quiz. So for the first question, we're asked to find the period, the phase shift, the vertical shift, and the vertical asymptotes. So we're given f of x. Let me write this as I read it. I'm going to factor it. So this equals 7, and then tangent of. So I'm going to pull out a 3 here, and inside you'd have x minus. How do I undo multiplication by 3? Well, I would multiply by a third or divide by 3. So pi over 2 times a third would be pi over 6. Close that down, close this down, and then plus 2. Again, if you want to check this because you're a little bit shaky, 3 times x is 3x, and then minus and minus. 3 times pi over 6 would be pi over 2. So once you have it in this form, it's a lot easier to get the information. Let me come down here and just write everything out, and then we'll go back. So the first thing is, when you think about the period, so that is very easy to get. For tangent or cotangent, the standard period is pi. So just start by writing that. Then you want to divide by the coefficient of x. Now, if it's in factored form, this has been pulled out. So it's going to be the number outside of the parentheses. But if you distributed this back in, you'd have a 3x there. So the coefficient of x is 3. So it's just pi over 3. That's all you have to do. Then when we think about the phase shift, you're going to look at this inside part here. So inside the parentheses, you want to undo what's being done to x. Here we have x minus pi over 6. So how do I undo that? I need to add pi over 6, which means I'm going to go to the right by pi over 6. So we're going to go to the right pi over 6. Then when you think about this part right here, this plus 2, and that's going to give me the vertical shift here. And we're going to go up by 2. So up by 2. So that's all the basic information. The other one that we're asked to find is the vertical asymptotes. Now, in the lesson and the practice tests, we were graphing. So let me distribute this back in. So we had something like 3x minus pi over 2. Again, all I did was say 3 times x is 3x, and then minus and minus, and then 3 times pi over 6. That's going to give me this pi over 2. So what we did was we took that argument and we said this is greater than negative pi over 2 and less than pi over 2. And we solve this inequality so we can get an interval to sketch our graph. Now with this, we're asked for a formula, so you really don't need to do this. All you have to do is pick one of these. So somewhere where tangent is undefined, it could be negative pi over 2, 3 pi over 2, whatever you want, it doesn't matter. And you can just set that equal. So get rid of this, and let me say that this is equal to negative pi over 2. And so you could add pi over 2 to each side here. This would cancel. You would get 3x is equal to, this cancels and gives me 0. And of course, if you divide both sides by 3, you get x is equal to 0. So what does that mean, x equals 0? It just tells us that at an x value of 0, this guy would be undefined, so you'd have a vertical asymptote. So let me write vertical asymptote here. I'm just going to put x equals 0. And you could check that real quick and see if it does work. So let's just say I put this as f of 0, and this equals 7 tangent of. Again, just put this in the form we started with. So 3 for x, I'm going to put a 0 there. And then we had minus pi over 2. Close that down, and then you have plus 2. Well, you know that 3 times 0 is 0. So you can say this is 7 tangent of 0 minus pi over 2. That's negative pi over 2. Close that down, and then plus 2. Well, notice that this part right here is going to become undefined. So tangent of negative pi over 2, that's undefined because it's the sine of negative pi over 2, which is negative 1, over the cosine of negative pi over 2, which is 0, and division by 0 is undefined. So we know that this part right here would be undefined. So you would stop if you were trying to evaluate that, and you would say, okay, well, there's going to be a vertical asymptote there. So I know that happens at 0, but it would also happen in an infinite number of other places. So how do we find that? Well, again, you just use your period. So you just say that things repeat every pi over 3 here. So I'm just going to add pi over 3 and then times n, where n is any integer. And adding 0 to something doesn't change it, so you can get rid of the 0. So really, it's just going to be pi over 3 times n, where n is any integer. So this would happen at 0, then it would happen at pi over 3, 2 pi over 3, 3 pi over 3, which is pi, 4 pi over 3, 5 pi over 3, so on and so forth. So that's a formula for all the vertical asymptotes. Again, a little bit different from what we did in the lesson, but not too hard to figure out. Let's grab that real quick, and let's come down here. So this is a bit hard to read because of the font size, but I'll just go through it with you and read it aloud. So we're just going to mark a lot of things out. So the period here is pi over 3. This one says the period is 3 pi. You can cross that out. This one down here says the period is 3 pi. You can cross that one out. Let me redo that. And then we want a phase shift that's going to go to the right by pi over 6. So you'll notice you do have that there. This one says right 3 pi over 2, so that's out. This one says left pi over 12, so that's out. If I read the rest of this, it says a vertical shift up 2, so that matches. And then the vertical asymptotes, you're going to have x equals pi over 3, so pi over 3, times n, where n is any integer. So this is the one that we want. All right, for question 2, we're asked to find the period, phase shift, and vertical asymptotes. So we have f of x is equal to 1/3, and then cotangent of. This one's really easy to factor. You have a 5 here and a 5 here. So if I pull that out, you're going to have x minus pi over 6. Close that down, close this down, then minus 4. Again, you can check. 5 times x is 5x, minus and minus. 5 times pi over 6 is 5 pi over 6. So thinking about the period, again, that's the first thing that I would do. It's the easiest thing. If this was distributed in, you'd have 5x there. So you want to take the standard period for either tangent or cotangent, which is pi, and then divide it by that coefficient of x, which would be 5. Again, in factored form, it would be outside the parentheses there. All right, the next thing we would do the phase shift. So we're looking at on the inside, again, you have this minus pi over 6. How do I undo that? I need to add pi over 6. So that means I want to go to the right. So to the right, pi over 6. Then for the vertical shift, you have minus 4. So we're just going to go down by 4. So vertical shift, we're going to go down 4. Okay, let me put a border. So in terms of the vertical asymptotes, again, with cotangent, let me distribute this back in. You'd have 5x minus 5 pi over 6. Again, when we graph this, we would say it's greater than 0 and less than pi. But you don't need to do that here, again, because we're trying to find a formula. So you could set this equal to 0, or you could set it equal to pi, or 2 pi, or anywhere where you know that there's going to be a vertical asymptote, and you just solve for x to see where it's going to be here. So we can just say this is equal to 0, and so we would add 5 pi over 6 to each side. So actually, let me just erase it from here and put it over here. I think that's pretty easy to do. And then I would just multiply both sides by a fifth. So let's say that we multiply by a fifth here and by a fifth here. And so this would cancel, and you'd have x is equal to, and let me do this in a different color, this would cancel, so pi over 6. And you can see, if you plugged in a pi over 6 there, pi over 6 minus pi over 6 is 0. 5 times 0 is 0, and the cotangent of 0 is undefined. So let me get rid of this. We know we would have a vertical asymptote at x equals pi over 6. But again, to get the other ones, or to get a general formula, just use your period. So things repeat every pi over 5. So plus pi over 5 times n, where n is any integer. That's all you need. So let's grab this. And again, very hard to read this, but I'm just going to do my best with you. So the period is pi over 5. So that's what we have here. This is 5 pi, get rid of that. We have it here, here. This is 7 pi over 3, get rid of that. The phase shift, we want right pi over 6. You have that here and here, but here it says right 5 pi over 2. So get rid of that. The vertical shift, we want down 4. So here we have down 4. Here we have up 1/3, so this is out. And then for the last one, we have the vertical asymptotes. X equals pi over 6, so pi over 6, plus pi over 5, so plus pi over 5, times n, where n is any integer. So this is the one that we want. All right, let's take a look at question 3. So we want to find the transformation. Let me come down here. And we're looking at f of x equals 4, cotangent of x over 3 minus 4 pi over 3 minus 1. Let me factor this first. I have a hint here, and I don't want to write over it yet. So we want to remember the inside of the function requires us to undo what is being done to x and in the reverse order. A lot of people have trouble with graphing transformations and the horizontal graphing transformations, to be specific. If you want to go back to the practice tests solution video, if you go to around the 17-minute mark, I looked at practice problem number 1 in extreme detail and just showed you why we need to undo things and go in the reverse order. So if you're still struggling, you can either rewatch it if you watched it already or watch it for the first time. So let me write f of x is equal to 4 cotangent of, pull out a 1/3. Inside you'd have x minus 4 pi. Close that down, close this down, then minus 1. Well, if I had a point on the original cotangent graph, so y equals cotangent of x, something like, let's say, pi over 4 comma 1, what would I need to do in order to get a point on this graph? So I would think about, here's y, and then here's x, and then I'll translate it over into the language that we need. So the first thing is, in terms of y, you want to multiply by 4. So multiply by 4. And the second thing is, you want to subtract away 1. So subtract 1. This is giving me a vertical stretch by a factor of 4. This is shifting me down by 1. Remember, this follows the order of operations. This is done first, this is done second. So that's why I have a 1 and then a 2. You multiply before you subtract. You can think about one of those points again on the cotangent graph, so something like pi over 4 comma 1. Again, this right here, you'd end up with just a 1. So you'd have 4 times 1, which is 4, and then minus 1, which would be 3. So that's all you're really doing here. You're multiplied by 4 first, and then you subtract away 1 when you think about getting the new y coordinate. Then when we think about x, this is where it gets tricky. You have to undo things, and you have to go in the reverse order to do that. So if we think about the order of operations, we plug something in for x here. We would first subtract away 4 pi, and then when we're done, we would multiply by 1/3. So I need to reverse that. So this right here would be done second, not first. And you have to reverse what's being done. So since it's minus 4 pi, you want to add 4 pi. This has to be done first, and you have to undo it. If it's multiplication by 1/3, to undo that, you need to multiply by 3. So what we would say here is that in terms of y, let me get rid of this, we're going to multiply by 4, which is a vertical stretch by a factor of 4, and then we're going to subtract away 1, which is shifting me down by 1. Let me go up, and let's look through the choices. So starting with our basic cotangent graph, vertically stretched by a factor of 4. So that one's good. You have shift down by 1. This one says vertically shrink by a factor of a 4th. Get rid of that. This one, vertically stretched by a factor of 4, shift down 1. Vertically stretched by a factor of 4, shift down 1. Vertically stretched by a factor of 4, shift down 1. So we really only eliminated 1. So for x, you have multiply by 3. That's a horizontal stretch by a factor of 3. And then add 4 pi. That's shifting to the right by 4 pi. So I'm looking for a horizontal stretch by a factor of 3. This says horizontally shrink by a factor of 1/3. That is out. This one, horizontally shrink. That one's out. Horizontally stretch by a factor of 3. Shift right 4 pi. This is the one you want. When you look at this one, it says horizontally stretch by a factor of 3, but then the shift right is 4 pi over 3, and that is wrong. So this is the one we want. So starting with our basic cotangent graph, vertically stretched by a factor of 4, horizontally stretched by a factor of 3, shift right 4 pi, and shift down 1. All right, let's take a look at question 4. We're asked to find the transformation. So let me write this out. So we have f of x is equal to 1/2, and then tangent of, I'm going to pull out the 2 here. So inside we have x plus How do I undo multiplication by 2? Well, you can multiply by a half. So this would be pi over 8. Pi over 4 times a half would be pi over 8. Close that down, close this down, then plus 2. You can distribute this and check if you want to. 2 times x is 2x, then plus, you have plus, and then 2 times pi over 8 is pi over 4. So what we're going to do is follow what we did in the last example. So let's think about what would happen to y, and let's think about, let me put a little border here, what would happen to x. So in other words, if you took a point on the basic tangent graph, so for example, you have something like negative pi over 4 comma negative 1, what would you need to do to x and what would you need to do to y to get the point on this graph here? So for y, this is done first and this is done second. So you would want to multiply by 1/2 and you would want to add 2. And you just follow the order of operations for that. You multiply before you add. So that's how we get that. All this is doing here is I'm taking my y coordinate and I'm multiplying it by a half, or you could say dividing by 2. And then after that, I'm adding 2. So when you multiply by a half, most books will say you get a vertical shrink by a factor of a half. Again, some people will say a vertical compression by a factor of 2. I don't care about the terminology. It's just understanding that when you have a y value, you're either going to divide it by 2 or multiply it by 1/2. Then this adding 2 here, that is just shifting me up by 2. So what you can do is come back here and mark some things off. So you'll see that starting with our basic tangent graph, vertically shrink by a factor of a half. So that's what we want. You have shift up everywhere, so you don't really have to check that. I'm going to put a little dot here. This one says vertically shrink by a factor of a half. This one says vertically stretch by a factor of 2. You can just mark that out. This one says vertically stretch by a factor of 2. You can mark that out. This one says vertically shrink by a factor of a half. That's what we want. Okay, let's go back and think about x now. This is the one that, again, is harder. Just remember, you need to undo things. So if I think about plugging something in for x, and then the first thing is I would add pi over 8 because I'm inside the parentheses here, just following the order of operations. So this would be done first, then you would multiply by 2 second. Again, I know you could distribute there. A lot of people get confused by that, but just say you didn't distribute, you would go inside the parentheses first and do the addition, and then after that you do the multiplication. So you want to go in the reverse order. So now this would be first, and this would be second, and you've got to undo things. So how do I undo multiplication by 2? Well, I can divide by 2, or I can multiply by 1/2. How do I undo adding pi over 8? I'm going to subtract pi over 8. So what is multiplying the x coordinate by 1/2 do? That's giving me a horizontal compression. You could say by a factor of 2, or you could say a horizontal shrink by a factor of a half. So either way, just understand that you're taking your x coordinate and you're dividing by 2 or you're multiplying by a half. It's going to be the same either way. Then the subtraction of pi over 8, that's going to shift me to the left by pi over 8. So coming back, if we look at these 3 guys that we have left, this one says horizontally shrink by a factor of a half, shift left pi over 8. So that's exactly what we want. Let me go ahead and circle that one. If you look at this one, it says horizontally stretch, so we don't want that. You can mark it out. This one says horizontally shrink by a factor of a half, so that's good. But then it says shift left pi over 4, so that's going to be wrong. So you can erase these if you want. They're just scratch work. And you can reread this and say, starting with our basic tangent graph, vertically shrink by a factor of a half, horizontally shrink by a factor of a half, shift left pi over 8, and shift up 2. All right, let's take a look at question 5. So again, we want to find the transformation. Let me write this. So we have f of x is equal to 1/4, and then tangent of, pull out an 8. Inside you'd have x minus, how do I undo multiplication by 8? I can divide by 8 or multiply by an eighth. Pi over 4 times 1/8 would be pi over 32. Close that down, close this down, then minus 3. Again, if you want to check, you can always say 8 times x is 8x, then minus and minus. 8 times pi over 32 is pi over 4. So this right here, let's put y. The first thing is you'd multiply by a 4th. That's 1. And then you'd subtract away 3. So this is for your y's. So this, let's go multiply by 1/4. And this, let's go subtract 3. So first and then second. That's why there's a 1 and then a 2. So if we think about what it means to multiply by a 4th, well, you're getting a compression by a factor of 4 vertically. Or you could say you're getting a vertical shrink by a factor of a 4th. Again, I don't care about the terminology. It's just I'm multiplying every y coordinate by a fourth, or I'm dividing by 4. Whatever you want to do is the same thing. Then you're subtracting away 3. That's just shifting me down by 3 units. So let's go up. So I want vertical shrink by a factor of 1/4. So it says that there. All of them say shift down by 3, so you don't have to worry about that. This one, vertically shrink by a factor of a fourth, vertically shrink by a factor of a fourth, vertically shrink by a factor of a fourth, and then vertically stretch by a factor of 4. This one's out. Okay, let's go on to x now. And again, when we think about what's being done, it's got to go in the reverse order. With the order of operations, I would work inside the parentheses first. So this would be done first, this would be done second, the multiplication would be done second. So now we reverse that, this is done second, and this is done first. So for the first thing, I want to undo multiplication by 8, so you can divide by 8 or multiply by 1/8. The second thing is I want to undo this minus pi over 32, so I need to add pi over 32. So this, multiplied by 1/8, that's giving me a horizontal compression by a factor of 8, or again, you could say a horizontal shrink by a factor of 1/8. And then here, this add pi over 32, that's shifting me to the right by pi over 32. This one says horizontally stretch, get rid of that, horizontally stretch, get rid of that, horizontally stretch, get rid of that. It's just going to be this one. So starting with our basic tangent graph, vertically shrink by a factor of a fourth, horizontally shrink by a factor of 1/8, shift right pi over 32, and down 3. So this is the one that we want. All right, let's take a look at the quiz. For the first question, we're asked to find the period, phase shift, and vertical shift. We're given f of x equals 7, secant of x plus pi over 3, and then minus 3. So for this one, we don't need to factor anything. The coefficient of x is just 1. So if you want the period, let me just write this out. It's just the standard period for secant, which is 2 pi. If you want the phase shift, well, you're going to look inside the parentheses. Let me just erase this. And you're going to say, how can I undo what's being done to x there? We have plus pi over 3. To undo that, you want to go minus pi over 3. That means I'm going to the left pi over 3. And then for the vertical shift, let me put this here. You're going to look at this part right here. You have minus 3. So you're just going to go down 3. And that's all it is. Let me slide down here a little bit and see if we can look at the choices. So the period of 2 pi, you're going to see that here and here. And then the next thing is the phase shift is left pi over 3. So you have that here, but not here. So let's get rid of that. And then the vertical shift is down 3. So this is what you want. So the period is 2 pi. The phase shift is left pi over 3. And the vertical shift is down 3. All right, let's look at question 2. So we want to find the period, phase shift, and vertical shift. And we have f of x equals 4 cosecant of 3x minus pi over 6, and then minus 2. So let me write f of x is equal to 4 cosecant of, let me put some brackets here, and then I'm going to pull the 3 out. So inside you have x minus. So to undo multiplication by 3, I could multiply by a third. So just take that pi over 6 and multiply by 1/3. So that would be pi over 18. So pi over 18, close that down, close this down, then minus 2. Okay, so for the period, again, what you want to do is take your standard period, which for secant or cosecant, doesn't matter which one you're working with, you're going to have 2 pi. So start with that. Then you want to divide by your coefficient of x, or if it's in factored form, it's the number outside the parentheses. Either way, you're dividing by 3. So it's 2 pi over 3. Then when you look at the phase shift, again, when it's in factored form, you just look inside those parentheses there and you say, how do I undo what's being done to x? Well, I have x minus pi over 18. To undo that, I want to add pi over 18. So I want to go to the right, pi over 18. And then when I look at the vertical shift, it's just that minus 2 out there. So for the vertical shift, it's just going to be down 2. All right, let's look through the choices. So I have a period of 2 pi over 3 here and then here. So just those two. And then for the phase shift, you want right pi over 18. So this says right pi over 18. This says left pi over 18. So this one's out. This is the one you want. Then for the vertical shift, it says down 2. So let me go ahead and circle that one. Again, what you're looking for is a period of 2 pi over 3, a phase shift that's going to be right pi over 18, and a vertical shift that's down 2. All right, let's look at question 3. So we want to find the transformation. We have f of x equals 1/3 cosecant of 4x minus 2 pi over 3. Okay, for these, again, I recommend just factoring it so you can think about it. Let me write on top of this. So f of x is equal to 1/3 and then cosecant of, pull out the 4. So inside you'd have x minus, all I would do here is multiply this by 1/4. So let's go 2 pi over 3 times 1/4. Let's go ahead and cancel this with this and put a 2 down there. So that would be pi over 6. So this is x minus pi over 6 inside. Close that down, close this down, and you don't have anything out here that would give you a vertical shift. So let me grab this. We can actually just go to a fresh sheet of paper and let me paste this in. What I like to do is write out what's happening to y and then what's happening to x. So you've seen me do this a million times. For y, it's very straightforward. You just have this 1/3 that's multiplying this guy. Again, there's nothing out here. So really, all you're doing is multiplying by 1/3. So it's very straightforward in terms of y. What you're getting is a vertical compression by a factor of 3. Or again, you might hear this as you're having a vertical shrink by a factor of 1/3. You're just taking your y coordinate and you're multiplying it by 1/3 or dividing by 3. Whatever you want to say there, it doesn't matter. So this one right here, you have two things that are going on. Again, for x, you've got to undo things. And as you've heard me say a million times, you've got to go in the reverse order. So when it's factored, you have inside of the parentheses that would be done first, and then you'd multiply second. So to reverse that order, now this right here is done first, and this is done second. So go in reverse because you're undoing stuff. How do I undo multiplication by 4? I want to multiply by 1/4, or you could divide by 4. So I'm getting a horizontal compression by a factor of 4, or you could say a horizontal shrink by a factor of 1/4. Again, I don't care how you say it. It's just a matter of taking your x coordinate and either dividing it by 4 or multiplying it by 1/4. Then for this part right here, how do I undo subtraction of pi over 6? I need to add. So I need to add pi over 6. Again, that's shifting me to the right, pi over 6. So putting everything together, you would say you have a vertical shrink by a factor of 1/3. Let's see, starting with our basic cosecant graph, vertically shrink by a factor of 1/3. So let me put a mark there. This one's out because it says vertically stretch by a factor of 3, so don't worry about that one. This is vertically shrink by a factor of 1/3. This one's 3, so that's out. This is vertically shrink by a factor of 1/3, so let me put a mark there. Let's go back. The next thing is, again, multiply by 1/4. You could say a horizontal shrink by a factor of 1/4. So looking through these three, here we'll say horizontally shrink by a factor of 1/4. So let's stay with that. Horizontally stretch by a factor of 4. That one's out. You can just erase this. Horizontally shrink by a factor of 1/4. Okay, so it's these two now. So let's go back. And remember that adding pi over 6 is going to shift me to the right by pi over 6. So for the final thing, this says shift right 2 pi over 3. So that's out. This one says shift right pi over 6. So this is what you want. So we'll circle that one. In other words, starting with our basic cosecant graph, you're going to vertically shrink by a factor of 1/3, horizontally shrink by a factor of 1/4, and shift right pi over 6. All right, for question 4, again, we want to find the transformation. Let me write this out. So we have f of x is equal to 1/4, and then secant of, I'm going to pull out the 1/2 there. So inside the parentheses, you're going to have x minus, how do I undo multiplication by 1/2? You can multiply by 2. So 2 times pi over 3 is just 2 pi over 3. Let's close all that down, and then minus 2. So let's just go ahead and go to another sheet, and I'll just paste this in. Again, you don't have to go through all this. A lot of times this is pretty obvious, but I think it's a little bit easier if we split this up and say, okay, what's going to happen to y? And then what's going to happen to x? Let's start with y because it's easier. You're multiplying this guy right here by 1/4. So that's going to give you a vertical compression by a factor of 4. Or again, you might say a vertical shrink by a factor of 1/4. So let me just put that we are multiplying by 1/4. Then this right here, this minus 2, that's going to shift me down by 2 units. So let me put subtract 2. All right, for x, again, you've got to go in the reverse order. You're trying to undo things, so you're going to do that in the reverse order. Then bring my 2 with me, so let me bring that down like that. So you would work inside of parentheses first and then multiply second. That's the order of operations. So to reverse that, now this would be first and this would be second. How do I undo multiplication by 1/2? Well, I want to multiply by 2. So what that's going to do is give me a horizontal stretch by a factor of 2. And then this right here, how do I undo subtraction of 2 pi over 3? Well, I want to add 2 pi over 3. So that's going to shift me to the right by 2 pi over 3. So maybe you can remember all this. You can write it down if you want. I'm just going to go back and forth. I'm going to start with this right here. So multiply by 1/4. Again, that's going to be a vertical shrink by a factor of 1/4. Let me come down here. So looking through, starting with our basic secant graph, vertically shrink by a factor of 1/4. So let me put a little mark there. This one says vertically stretch by a factor of 4. You don't want that. Vertically shrink by a factor of 1/4. Yes. and then vertically stretch by a factor of 4. You don't want that. Vertically shrink by a factor of a fourth. Yes. So 1, 2, and 3. Let's go back down. Let's think about this. So we're going to multiply by 2. This is in terms of x. That's a horizontal stretch by a factor of 2. And then this add 2 pi over 3, that's a shift to the right by 2 pi over 3. So looking for a horizontal stretch. This says horizontally shrink, so we don't want that. This one says horizontally stretch by a factor of 2, shift right 2 pi over 3. This is the one we're going to want. You can also see the shift down by 2, but I'll go back for that in a moment. This one says horizontally shrink by a factor of a half, so this one's out. This is the one that you want, this one right here. Let me go back and show you. Remember, you had this subtract away 2, this part right here. That's the shift down by 2. So we'll come back up and just read through this. So starting with our basic secant graph, we want to vertically shrink by a factor of a fourth, horizontally stretch by a factor of 2, shift right 2 pi over 3, and shift down 2. All right, for question 5, we're asked to find the transformation. So let's write this out. We have f of x is equal to 3, and then secant of, I'm going to pull out a 1/5 here. And so inside the parentheses, you're going to have x plus, if I'm pulling out a 1/5, again, how do I undo multiplication by a fifth? You'd multiply by 5. So 3 pi over 4 times 5, that's going to be 15 pi over 4. Close that down, close this down, then minus 4. Okay, so once again, you could do it from where it is. I think it's a little bit easier to bring it down here and just spend a few minutes going through each thing. So let's talk about y. You have 1 and then 2. And let's talk about x. So 1 and then 2. So for y, again, it's always so straightforward. You have this 3 that's multiplying this guy. So we're just going to multiply by 3. So that's a vertical stretch by a factor of 3. Then you have this minus 4 out here. That's just going to shift me down by 4. Let me put that we're subtracting 4. Looking at the x, again, you've got to go in the reverse order. This is first because you're inside the parentheses. This would be second. You're multiplying. So to reverse that, this would now be first, and this would be second. Go in the reverse order because you're undoing things. How do I undo multiplication by a fifth? Well, I would multiply by 5. And what's that going to do? It's going to give me a horizontal stretch by a factor of 5. And then this right here, how do I undo addition of 15 pi over 4? I'm going to subtract away 15 pi over 4. So subtract 15 pi over 4. That's going to shift me to the left 15 pi over 4. Now, if you go back up, we want to first start with the vertical stretch by a factor of 3. Let's read these. So starting with our basic secant graph, we have vertically stretched by a factor of 4. So that's wrong. We're looking for vertically stretched by a factor of 3. This is vertically shrink by a factor of a third. So that's out. This one says vertically stretched by a factor of 3. Vertically stretched by a factor of 3. This says vertically shrink by a factor of a third. So it's just these two right now. So let's go back. Here we would say multiply by 5, and this is in terms of x. Again, that's horizontally stretching me by a factor of 5. So this says horizontally stretched by a factor of 5, horizontally stretched by a factor of 5. So those two things say the same thing. Now we have subtract 15 pi over 4. Again, that's going to shift me to the left by 15 pi over 4. And remember, this subtract away 4 here. This is in terms of y. This shifts me down by 4. So I want to go shift to the left 15 pi over 4 and then shift down by 4. So this one says shift right. So I don't want that. This one says shift left 15 pi over 4 and shift down 4. So this is the one that I want. This guy right there. So starting with our basic secant graph, vertically stretched by a factor of 3, horizontally stretched by a factor of 5, shift left 15 pi over 4, and shift down 4. All right, let's take a look at the section quiz. For the first question, we're told that the basic sine function, so this is our y equals the sine of x, is graphed as a dashed curve in purple over one cycle. So this is from 0 to 2 pi, with both being included. So you'll see that here. I know the picture is very small. I gave you a link on Desmos. And when we go to the next sheet, I'll have a bigger image for you to look at. So we have find the function that represents the graph in red. So this guy right here. I have a note. Don't worry about a domain restriction. We are graphing only one cycle of each to make things easier to see. So we are not going to put a domain restriction in when we list our function. So let's come down and let's look at what we have. So this guy, again, this dashed curve in purple, this is the regular sine function. So this right here is just, you can go f of x is equal to the sine of x. We know our points for that. So let me just scroll down a little bit so I have enough room to fit this. We have our 0, 0. We have our pi over 2, 1. We have our pi, 0. We have 3 pi over 2, -1. And then we have our 2 pi, 0. So we should know these points. Here's your 0, 0, your pi over 2, 1, your pi, 0, your 3 pi over 2, -1, and then your 2 pi, 0. Now, what you're expected to do here is look at this graph and look at the points that you're given. We're going to have, at the beginning of this cycle here, 0, 0. So there's no change. The x value is 0, the y value is 0. So it's the same. When we go to the quarter of the way through, you're going to see that that's pi, 2. So this is pi, 2. Now notice that I can get that by multiplying this by 2 and this by 2. In other words, pi over 2 times 2 is pi, and 1 times 2 is 2. So what you're actually getting, you can tell this right away, you have a vertical stretch by a factor of 2, and you have a horizontal stretch by a factor of 2 as well. If you continue that pattern, and you say, okay, I multiply this by 2, I get 2 pi, and if I multiply 0 by 2, I still have 0. So you'll notice that on the red graph, you have this 2 pi, 0. So that's right there. And then again, continuing this, if I multiply 3 pi over 2 times 2, I'm going to get 3 pi. If I multiply negative 1 by 2, I'm going to get negative 2. So come down here, you have this 3 pi, negative 2. And then lastly, if we multiply 2 pi by 2, we get 4 pi. If we multiply 0 by 2, we get 0. So this is 4 pi, 0 there. So how would you take this guy right here and say that we're going to have a vertical stretch by a factor of 2? Well, you would say that this is f of x is equal to 2 times your sine of, how do I get a horizontal stretch by a factor of 2? Again, this is the tricky one. A lot of people will make the mistake and put a 2x in there, but that's not what you want. If you put a 2x in there, that's giving you a horizontal compression, right? So you could say by a factor of 2, or you could say a horizontal shrink by a factor of a half. The terminology doesn't matter there. You would be taking each x value and dividing by 2 or multiplying by a half. So what you actually want to do is put this as 1/2, and I didn't make this to where it would fit. So you want to put 1/2 times x, because now what you're doing to undo what's being done to x, you need to multiply by 2. That's going to give you the horizontal stretch by a factor of 2. Again, with 0, it's still going to be 0. So you don't have to worry about that. If I plug in a 0 here, 1/2 times 0 is 0. The sine of 0 is 0, and 0 times 2 is 0. So you get 0, 0 as well. Then for something like this, let's say you did f of, let me slide down a little bit. Let's just plug in pi. What do we get? So it's 2 times the sine of, you have 1/2 times pi. Well, 1/2 times pi is going to get me to this pi over 2 here. So this becomes 2 times the sine of pi over 2. Well, we know that the sine of pi over 2 is 1. So this becomes 2 times 1, which is 2. So that's how you get this pi, 2. Again, just multiplying this by 2 and this by 2. So a horizontal stretch by a factor of 2 and a vertical stretch by a factor of 2 as well. So you want f of x equals 2 sine of 1/2 x. So let's come down here and look at the choices. So this is what you want. So your f of x equals 2 sine of 1/2 x. All right, let's take a look at question 2. So we have here that the basic cosine function, so y equals the cosine of x, is graphed as a dashed curve in purple over one cycle. So from 0 to 2 pi, with both being included. We want to find the function that represents the graph in red. Again, I have this note, don't worry about a domain restriction. We are graphing only one cycle of each to make things easier to see. But these graphs, you can extend them to the left or the right as much as you want. We're just doing this for the purposes of making it a lot easier to figure out what's going on. Okay, so let's go down to where I have a bigger copy of this image. And again, if you're having trouble seeing this, depending on the device you're using, just click the link for Desmos. It will show you the answer, but again, if you're self-studying, you should be okay with that. You need to be able to figure out, how would I get this answer on my own? So looking at this guy, you see that they both start at 0, 1. So that tells me immediately that I'm not going to have any type of horizontal shift. But what you can see is that this guy clearly is compressed horizontally. Nothing is happening vertically. So there's no vertical shift up or down, and there's no vertical stretch or compression. So what I would do is just look at these guys and say, okay, well, if this starts at 0, 1, so this is 0, 1, and again, this is going to go 0, 1. So there's no change with the start. But if I look at a quarter of the way through, well, for this one, it's pi over 2, 0. We know that point. So this is pi over 2, 0. And what does it do here? Well, we're going to be at pi over 4, 0. So pi over 4, 0. So already I can see that to go from here to here, I multiplied by a half, or you could say you divided by 2. So what's happening is this guy is getting horizontally compressed by a factor of 2, or again, a lot of people will say it has a horizontal shrink by a factor of a half. So it doesn't matter which terminology you want to use, just realize that you're taking your x coordinate, so in this case it's pi over 2, and you're dividing by 2 or you're multiplying by a half. In this case, that would give you pi over 4. So if you keep doing that, let me move this down here so maybe it would fit, I think maybe like this, and then maybe slide down just a little bit, and I can put it like that. So the next point would be pi, -1 on the cosine graph. So that's going to be right here. Now, where is that going to go? Again, if we take the x-coordinate and divide by 2, well, that means it would be pi over 2, comma, -1. And again, you see that right there. Then you would have your 3 pi over 2, comma, 0. So now if I multiply by a half, you would have 3 pi over 4, comma, 0. And that's going to be right there. So you have this one going to this one. And then lastly, you have that 2 pi, comma, 1. And if I divide this by 2, or again, multiply by half, this would be pi, comma, 1. So you go from 2 pi, comma, 1 to this pi, comma, 1. So all we're really doing here is we're dividing each x-coordinate by 2. So I'm getting a horizontal, let's just say compression by a factor of 2. Once again, if you want to say a horizontal shrink by a factor of a half, that's fine as well. So looking at how we would set this up, again, when you have something being done to x, it's always the opposite. So I want to put f of x equals the cosine of, do I want to put 1/2 x since I'm multiplying each x coordinate by a half? No, I want to put 2x. I want to put 2x there because I need to undo what's being done to x. In other words, if I plugged in, let's say pi over 4 here, well, let me just show you this. So f of pi over 4, this would be equal to the cosine of 2 times pi over 4. Again, 2 times pi over 4 would be pi over 2. So I'm getting to this right here. And the cosine of pi over 2 would be 0. In other words, this becomes the cosine of pi over 2. So this matches this now, which gives me 0. So let me erase this, and this, and this. And let's go with pi over 2. So if you plug that in, again, if you're multiplying that by 2, 2 times pi over 2 would just give you pi. And let me erase this. The cosine of pi we know is -1. So again, you're plugging in this pi over 2, and you're going to end up with this pi at the end of the day. You're going to have cosine of that pi, and that's going to give you that -1 right there. So this is the one you want. You want f of x equals the cosine of 2x. So looking through the choices, you're going to want this one right here. So f of x equals the cosine of 2x. Okay, let's take a look at question 3. We are asked to find the amplitude, period, phase shift, and vertical shift. So we have f of x is equal to 2 cosine of this 5x. So that's your argument there. And then you have -1. Okay, so the amplitude is really easy. You just take the absolute value of this number out in front. So for the amplitude, this is going to be the absolute value of 2, which is 2. So if you look at the choices, let me slide down so we can see that. We have an amplitude of 2 here, here, and here. So this one right here, amplitude of 5, and this one right here, amplitude of 4. You can just mark those out now. The other thing we want to do is find the period. So the standard period for cosine is 2 pi, and then you want to divide by the coefficient of x, which is 5. So it's 2 pi over 5. So that is going to mark out this one, because it says pi over 5. And then this one and this one, they have a period of 2 pi over 5, so that's okay. Then we want to find the phase shift. So let me abbreviate that. So phase shift, what is that going to be? Well, when you look inside the parentheses, you just have 5x there. You don't have anything like 5x plus something or 5x minus something. So really, horizontally, the only thing we're doing is we have a horizontal compression by a factor of 5, or you could say a horizontal shrink by a factor of a fifth. But we don't have a phase shift. So the answer here would be none. So if we look at this, we see phase shift of none. And here it says left pi over 5. So this one's out. So this is the only choice that's left. Of course, the vertical shift, if you think about that, you have this -1 here. That's going to go down 1. So this is what we want. An amplitude of 2. A period of 2 pi over 5, a phase shift that's none, and a vertical shift that's down 1. So this is the one we want right there. All right, let's take a look at question 4. We want to find the amplitude, period, phase shift, and vertical shift. So we have f of x is equal to 9 sine of, we have this 5x minus 3 pi over 19, and make this 3 better here. Close that down, and then plus 4. Again, when you get something like this, I would factor it. It's not required, but it just makes finding the phase shift much easier. So f of x equals 9, and then you have sine of. You're going to pull out a 5. So inside you have x minus. How do I undo multiplication by 5? I would multiply by a fifth. So this is 3 pi over 19 times 1/5. Well, 19 times 5 is 95, so this would be 3 pi over 95. Let's do that like that. Close that down, close this down, then plus 4. You can get rid of this form if you want, or you can keep it. It doesn't matter. Let's move this up here just a little bit. And then let me slide down so all the answers are going to show on the screen. Hopefully this one doesn't get cut off. In terms of the amplitude, again, it's just the absolute value of that number that's out in front. So the absolute value of 9 is 9. So you have amplitude of 9, 9, 9, 9, and 9. So we really can't eliminate anything off that. Then for the period, it's the standard period, which is 2 pi, divided by the coefficient of x if it's not factored, or the number outside the parentheses if it is. So it's 2 pi over 5. Let's see, we've got that here, we've got that here, we've got that here, we've got that here, but not here. This one says period of 5 pi over 2, so get rid of that. Then in terms of the phase shift, again, the reason we factor is it makes it a lot easier because you can just go inside the parentheses here and say, what do I need to do to undo what's being done to x? Well, there you have x minus 3 pi over 95. So to undo that, I want to add 3 pi over 95, which means I'm going to the right. 3 pi over 95. So let's look. Right 3 pi over 95. This one says left. You get rid of that. This one says right 3 pi over 19. That's out. This one says left 3 pi over 19. That's out. And so this is the only choice. If you look at the vertical shift, so vertical shift, you have plus 4. Again, that's going to go up 4. So this is the one we're going to want. The amplitude is 9. The period is 2 pi over 5. The phase shift is right 3 pi over 95. And the vertical shift is up 4. All right, let's take a look at question 5 now. So we want to find the period, phase shift, vertical shift, and vertical asymptotes. So what we have is f of x is equal to 2 tangent of, we have this 3x minus 17 pi over 12. And then we'll close that down and say plus 1. What I would do is factor this. Let me actually take this to another sheet because we need some room to work when we want to find the asymptotes. So for this one, again, we'll go f of x is equal to 2 tangent of, go ahead and pull out the 3. Inside you'd have x minus, how do I undo multiplication by 3? I just multiply by a third. So you'd have 17 pi over 12 times 1/3. So this becomes 17 pi over 36. Close that down, close this down, then plus 1. Okay, you can erase this form. You don't need it. So we were asked for the period. So let me start with that. So this is the period. Again, you have to remember that with tangent and cotangent, the standard period is pi. So you want to go pi divided by, again, the coefficient of x if it's in unfactored form, or the number outside of the parentheses if it's been factored. So it's pi over 3 here. Then we want the phase shift. So in this case, you have this minus 17 pi over 36. So that means I want to go to the right, 17 pi over 36. Again, always undo things on the inside. I want to add 17 pi over 36 to undo what's being done to x there. So let me write that this is right, 17 pi over 36. Then for the vertical shift, this is just coming from that plus 1 there. So we're just going up 1. Now, in terms of the asymptotes, let me put V period, A period for vertical asymptotes. In the lesson, we talked about finding 2 consecutive vertical asymptotes. So you'd set up an inequality to do that. But for this one right here, what I would do, let me go back to the form of this being 3x minus 17 pi over 12. That's for the argument for the tangent function. What I'm going to do is I'm just going to set this right here equal to negative pi over 2. Where does that negative pi over 2 come from? Well, again, when you look at the standard y equals tangent of x, you know you have a vertical asymptote at negative pi over 2 and pi over 2. So you can just take this negative pi over 2 right here and set it up to where you solve for x and you'll find one of them, and then you just use the period to find additional ones. So what I'm going to do is just add 17 pi over 12 to both sides of the equation. So this right here would cancel. Let me slide down here a little bit. And so I can just erase this to make it a little bit cleaner. For this one, let me just say that I'm going to multiply by 6 over 6 so that I have a common denominator. And let me make this 6 better here. So this would end up being that 3x is equal to negative 6 pi over 12 plus 17 pi over 12. Negative 6 pi plus 17 pi, that's 11 pi. So this would be 11 pi over 12. So you now have 3x equals 11 pi over 12. Well, if I want to isolate x, you can divide both sides by 3. But because we have a fraction over here, it's a lot easier to just multiply by 1/3. So let me do it that way. So this would cancel with this. And so now you have x is equal to 11 pi over 12 times 1/3. is 11 pi over 36. So you'd have a vertical asymptote at x equals 11 pi over 36. But how do you get the rest of them? So you want to use your period here, which is pi over 3. So I'm just going to go plus pi over 3, and then times n, where n is any integer. Okay, let's grab all of this and come down here and see if we can get a match on anything. So the period is pi over 3. So you have that here. This is 2 pi, so this is out. 2 pi over 3, that's out. Pi over 3 and pi over 3. The phase shift is going to be right 17 pi over 36. So this is out. And then this one says left 17 pi over 36, so this is out. This one says right 17 pi over 36. We already know, since we eliminated everything else, this is going to be what we want. But let's keep going through and see if we can get everything else to match. So the vertical shift is up 1. So we have that there. Then when we look at the vertical asymptotes, again, you have this formula, which is x equals 11 pi over 36, and then plus pi over 3, that's your period, times n, where n is any integer. So this is what we want. All right, for question 6, we want to find the period, phase shift, vertical shift, and vertical asymptotes. So we're looking at f of x is equal to 7 cotangent of, we have 2x minus 2 pi over 5, and then minus 3. Let me make this 3 better here. Let me go ahead and grab this. And we need a lot of room, so let me paste this in here. Again, I would factor this. If you don't want to, you don't have to. This one's really easy to factor. So f of x equals 7 cotangent of, pull out the 2, and inside you would just have x minus pi over 5. Sounds really straightforward. And then outside here, you have this minus 3. Let me make that better there. So what I would do is start off with the period. Again, when you work with tangent or cotangent, the standard period is pi. So you have to remember that. So for the period here, we're starting with pi, and then we're dividing by, again, the coefficient of x here, if it's not factored, or the number outside of the parentheses if it is factored. So it's just pi over 2. Then for the phase shift, again, this is why I like the factor, you can just come inside the parentheses here and say, how do I undo what's being done to x there? So it means I want to add pi over 5 to undo that. So that's going to go to the right, pi over 5. Then when I think about the vertical shift, so the vertical shift, you have this minus 3 here. That's just going to go down 3. So these are very straightforward. In terms of the asymptotes, the vertical asymptotes here, let me get rid of this one. I'm going to work with this form here. Again, all you have to do is take that argument, so this 2x minus 2 pi over 5, and think about where are the asymptotes on the basic cotangent function. So we know that you'd have one at 0 and pi. Of course, there's an infinite number of them, but let's just take those. So 0 and pi. So I'm just going to take 0. So I'm just going to set this equal to 0. And let's bring this down here so we have some room to work. Let me put vertical asymptotes here so we don't forget what we're working on. Let me paste this in here. Just solve this for x. So I would add 2 pi over 5 to both sides. So 2x is equal to 2 pi over 5. And then multiply both sides by 1/2. So that's going to cancel. That's going to cancel. So you get x equals pi over 5. So we're going to start with that. I know I have a vertical asymptote where x is equal to pi over 5. How do I get the rest of them? Well, you're just going to use the period. The period is pi over 2. So you just go plus pi over 2 times n, where n is any integer. So that's all you're going to do. Let me go ahead and grab this and come up here and paste this in. So I'm looking for a period of pi over 2. So you do have that here. You have that here, and then nowhere else. So cross this out, and this out. So coming up here, we want a phase shift that's right pi over 5, so you have that here and here. We want a vertical shift that's down 3, have that here and here. So it's going to come down to the vertical asymptotes. So you have x equals pi over 5 plus pi over 2 times n, where n is any integer. Let me move this out of the way so you can see this, and move this over here maybe like that. So it's going to be this one, right? This one says x equals 3 pi over 2 plus pi over 2 times n, where n is any integer. So this one's out. This is the one that you want. So you want to say the period is pi over 2, the phase shift is right pi over 5, the vertical shift is down 3, and then the vertical asymptotes, it's x equals pi over 5 plus pi over 2 times n, where n is any integer. All right, let's take a look at question 7. So it says, consider the following function. We have f of x equals the cosecant of x, then minus 5. Let me write this out so it's crystal clear. So f of x equals the cosecant of x, so x is the argument, and then you have minus 5. So this represents the cosecant function that's been shifted down by 5 units. So then we have and its guide function. So f of x equals the sine of x, then minus 5. So again, that's the sine function shifted down by 5 units. This says, which of the methods described below would correctly allow us to find the vertical asymptotes for the cosecant function given? So let me just read through things, and we're going to think about this, and then I'll show you a graph. So use the x-intercepts of the guide function. Well, that would work if we had f of x equals the sine of x. We don't have that here. This has been shifted down by 5 units. Let me show you that real quick. If you want to do this with me, you can just go to Desmos and just key in f of x equals cosecant of x, then minus 5, and then f of x equals sine of x, and then minus 5. Just make sure to wrap your argument there so that Desmos doesn't think you want the cosecant of x minus 5 as a quantity. Okay, so you want the argument to be x in each case. So if you look at your sine graph, that's this dashed curve here in green. This guy's been shifted down by 5 units. If I come over here and I get rid of that, you see that I went back to the normal where we have our x-intercepts at 0, pi, 2 pi, 3 pi, so on and so forth. So basically pi n where n is an integer. Let me put this back in. So that shifts me down by 5 units. So you see that you don't have x-intercepts here, right? Because it's been shifted down. So you can't use the x-intercepts if you have a vertical shift up or down. So let's go back. The next thing it says is use the y-intercepts of the guide function. That's obviously not going to work. Then here we come to use the shift down by 5 units to find the new midline. This will occur at y equals negative 5. Any point on the guide function that intersects this midline will have an x value that is undefined in the cosecant function and will create a vertical asymptote. So this is the one we actually are going to want. Let me show you that real quick. If we look, this line right here in black, this is y equals negative 5. So if you look at anywhere where this touches, so for example, we have a point there. This is pi comma negative 5. Here's a point here, which is 2 pi comma negative 5. Again, all we did was we took the sine function and we shifted it down by 5 units. So the x value where you would normally get an x-intercept, where it's 0, pi, 2 pi, 3 pi, 4 pi, so on and so forth, well now the y value is not 0, it's going to be negative 5 because it's been shifted down by 5 units. So for any point on that sine function where the y value is negative 5, well, we're going to have an x value there that would be undefined if you plugged it into the cosecant function, so you would have vertical asymptotes for those values. It's still going to be your 0, pi, 2 pi, 3 pi, so on and so forth, so pi n where n is an integer, but just realize that the new midline here is y equals negative 5, it's not y equals 0. Now let's go back. And let me show you the other two choices. It says use the shift right by 5 units to find the new vertical asymptotes. You do not have a shift right, so that's obviously not going to work. Then it says use the period of 2 pi and the fact that the vertical asymptotes occur at 1/4 of the way and 3/4 of the way through the cycle of the guide function. This is not the case when you think about the sine function. If we go back, if you think about the sine function, again, let me get rid of this. You have x-intercepts at the beginning, so that's 0, 0. The middle, that's pi comma 0, and the end, so that's your 2 pi comma 0. When you think about 1/4 of the way and 3/4 of the way through, that's for the cosine function. So if you wanted to use the technique that we talked about in the lesson, where you go at the beginning, the middle, and the end, that would actually work, right? So the beginning is 0, the middle is pi, and the end is 2 pi. So you can do that as well. That's an alternative approach. But you can't say 1/4 of the way through and 3/4 of the way through. So that would be something you would work with the cosine function and the secant function. So if this was phrased to where it said beginning, middle, and end, that would be a valid choice as well. But it doesn't say that. It says 1/4 of the way and 3/4 of the way. So that one's out. So this is what you want right here. All right, let's take a look at question 8. So here we want to find the transformations required to obtain the graph starting with a basic trig function. Okay, so let me write this out. We have our f of x is equal to 5 and then secant of. Inside the parentheses, you have 8x minus 5 pi over 6, and then you have this minus 4. Okay, let me go to another page, just so we have a lot of room to work. What I would do is factor this, and then I would think about x and y separately in terms of what needs to be done. So let's go ahead and write this as f of x is equal to 5 and then secant of. I'll put some brackets here. I'm going to pull out an 8. So inside the parentheses, you'd have x minus. How do I undo multiplication by 8? Well, I could multiply by 1/8. So this is 5 pi over 6 times 1/8. So that gives me 5 pi over 48. So let's write that in there. Close that down, close this down, then minus 4. Okay, you can get rid of this form right here. You don't really need it. you're just going to think about what am I going to do in terms of y, and then what am I going to do in terms of x. So y is very straightforward. You have this right here, this 5 that's multiplying this guy right here. So that's going to give me a vertical stretch by a factor of 5. Let me just put here that you're going to multiply by 5. So very straightforward. Then this minus 4 outside here, that's just shifting me down by 4 units. So let me put subtract 4. In terms of x, again, this is where people have trouble. You have to undo what's being done to x, and to undo things, you have to go in the reverse order. So if I was plugging something in for x, I would first work inside the parentheses. So I would subtract away 5 pi over 48, and then I would multiply by 8. So this would be first, this would be second. If I'm going in the reverse order, now this is first and this is second. How do I undo multiplication by 8? Well, I want to multiply by 1/8. How do I undo subtracting away 5 pi over 48? Well, I want to add 5 pi over 48. Well, multiplying by 1/8, if you think about it, it's going to give you a horizontal, you could say compression by a factor of 8, or some people will say a horizontal shrink by a factor of 1/8. Again, the terminology doesn't really matter as long as you understand what's going on. You're taking your x-coordinate and you're either dividing it by 8 or multiplying it by 1/8. Then this add 5 pi over 48, that's a shift to the right by 5 pi over 48. So let's go back up and look at our answer. So this multiply by 5, that's a vertical stretch by a factor of 5. We're going to start with that. So here we have starting with secant of x, vertically stretch by a factor of 5. So you have that here as well. This one says vertically shrink by a factor of 1/5. That's out. This one is vertically shrink. That's out. This one is vertically stretch by a factor of 5. Let's go back. So I'm going to come over here. It says multiply by 1/8. Again, this is in terms of the x values. So that's going to be a horizontal, let's go shrink by a factor of 1/8. So looking at this, this says horizontally stretch by a factor of 8. So that's going to be out. This says horizontally shrink by a factor of 1/8. This says horizontally shrink by a factor of 1/8. Okay, then this part right here, where we're adding 5 pi over 48, again, this is in terms of x, that's going to be a shift to the right by 5 pi over 48. So here it says shift right 5 pi over 6, so that's out. And here it says shift right 5 pi over 48, so we're going to want this one. Now the last part of that says, and shift down 4. So if you come back here, in terms of y, remember you have this minus 4 out here, that's subtracting away 4, that shifted me down by 4 units. So starting with secant of x, we have vertically stretch by a factor of 5, horizontally shrink by a factor of 1/8, shift right 5 pi over 48, and shift down 4. Okay, let's take a look at question 9. So again, we want to find the transformations required to obtain the graph starting with a basic trig function. So we're going to have f of x is equal to this 1/3 and then secant of, let's go ahead and factor it now. So inside the parentheses, you have x over 3 plus 5 pi over 6. I'm going to pull out a 1/3. So inside the parentheses, you would have x and then plus. How do I undo multiplication by a third? Well, you would multiply by 3. So you would have, let me write this out. So 5 pi over 6 times 3. Let's go ahead and cancel this with this and put a 2 down there. So that would be 5 pi over 2. So let's close all this stuff down. And then you have plus 1. Now you can do it from here if you want. I think maybe for the sake of completeness, we'll just bring it to another page and just go through this again. So you have 2 things you're doing for y, and then 2 things you're doing for x. So in terms of y, again, it's very straightforward. You have the 1/3 that's multiplying the secant guy here, and that's giving you a vertical compression by a factor of 3, or you could say a vertical shrink by a factor of a third. Again, just realize that you're taking each y coordinate and dividing it by 3 or multiplying by a third. Let me just put multiply by 1/3. Then this plus 1 out here, that's just going to shift me up by 1. So let me put add 1. In terms of x, again, we're undoing things, so we're going in the reverse order. So this is 1 and this is 2. How do I undo multiplication by a third? Well, you'd want to multiply by 3. So that's going to give me a horizontal stretch by a factor of 3. Then how do I undo adding 5 pi over 2 here? Well, I want to subtract away 5 pi over 2. So let me write subtract 5 pi over 2. Let me make the 5 better. So that means I'm going to shift to the left by 5 pi over 2. Okay, so let's go back. Maybe we could just grab this so we don't have to go back and forth. Okay, let's paste this in. It's going to be a little bit hard to read, but we'll do our best. So here I have starting with secant of x, vertically shrink by a factor of a third. So that matches what we have here. So we're going to put a dot here. This one says vertically stretch by a factor of 3. So this is out. And then these would all say vertically shrink by a factor of a third. So this one, and this one. Now coming over here where it says x, the first thing is to multiply by 3. So again, that's a horizontal stretch by a factor of 3. So right here it says horizontally stretch by a factor of 3. Horizontally shrink, so you can get this one out of the way. This one is horizontally shrink, get that out of the way. And this one says horizontally shrink, get that out of the way. So really only the top one here is left. If you look at this part right here, it says shift left 5 pi over 2. So that matches this. Again, you have that subtract away 5 pi over 2. And then if we come back over here, it says and shift up 1. That adding 1 here that we have for y as the second thing we're doing, that's a shift up by 1. So this is the one that we want, this first choice here. So let's just go ahead and circle it. And we'll say that starting with secant of x, vertically shrink by a factor of a third, horizontally stretch by a factor of 3, shift left 5 pi over 2, and shift up 1. All right, let's take a look at question 10. So we want to find the transformations required to obtain the graph starting with a basic trig function. So we have f of x is equal to 7 tangent of, again, let me just factor this now. So I'm going to pull out a 3, and then inside you would have x plus. How do I undo multiplication by 3? Well, I would need to multiply by a third or divide by 3. So you have pi over 3 here. Let me write this out. So pi over 3 times 1/3. So that would be pi over 9. So this right here would be pi over 9. And then we'll close those guys down. And then you have minus 3. Let me go to another page. And again, we'll just write this out. Maybe you don't need this at this point, but I think a lot of people find it helpful. So I'll just take the extra time to do it. So for y, again, you have this 7 out in front that's multiplying this tangent guy. So we're going to put multiply by 7. So what is that giving me? A vertical stretch by a factor of 7. Then when we look at this minus 3 out here, so we're going to subtract 3. That's a shift down by 3 units. In terms of x, again, you have to undo things in the reverse order. This will be 1. This will be 2. How do I undo multiplication by 3? I can divide by 3 or multiply by 1/3. Let's just go ahead and say that's going to be a horizontal shrink by a factor of a third. Again, if you want to say a horizontal compression by a factor of 3, that's up to you. Then this guy right here, we have this plus pi over 9. So I want to undo that. That means I need to subtract pi over 9. That's going to shift me to the left, pi over 9. So let me grab this again. So we're starting with tangent of x, vertically shrink by a factor of 1/7. So in terms of y, we put multiply by 7. So that's going to give me a vertical stretch by a factor of 7. So this one's out. This one says vertically stretch by a factor of 7. And then the same thing here, and then here, and then here. So those are good so far. When we go over to x, it says multiply by 1/3. Again, that's going to give me a horizontal shrink by a factor of a third. This one is horizontally stretch, so you can get rid of that. Horizontally stretch, get rid of that. Horizontally shrink by a factor of a third. And this one says horizontally shrink by a factor of a third. So let me get rid of this right here and there. Now the next thing is you have this subtract pi over 9. And this is in terms of x. So that's shifting to the left by pi over 9. So let's see. We have shift right. So that's out. And this one says shift left pi over 9. And then it says and shift down 3. Again, you have this subtract away 3 that's coming from right there. And so that's shifting me down by 3 units. So that's the one we want. Let me get rid of this. And we'll just circle it. So again, starting with tangent of x, vertically stretch by a factor of 7, horizontally shrink by a factor of a third, shift left pi over 9, and shift down 3. All right, let's take a look at question 11. We want to find the transformations required to obtain the graph starting with a basic trig function. So let's write out that we have f of x is equal to 6 and then sine of, let me pull out that 3 now. So inside you have x plus, again, to undo multiplication by 3, you can multiply by a third. So pi over 4, let me write this out. So pi over 4 times 1/3, that would be pi over 12. So this right here is pi over 12. Let's close everything down. And then you have minus 5. Let me make the bracket a little bit better there. Let me grab this and paste this in here. So let's go y and let's go x. So for y, again, you have the 6 out in front that's multiplying the sine guy. So we'll just put multiply by 6. So that's a vertical stretch by a factor of 6. You have this minus 5 on the outside here. So subtract 5. That's going to give me a shift down by 5. In terms of x, again, this is 1 and this is 2. How do I undo multiplication by 3? I would multiply by a third. So multiply by 1/3. So you can have a horizontal shrink by a factor of a third, or again, you can say a horizontal compression by a factor of 3. This right here, if I want to undo plus pi over 12, I want to go minus pi over 12. So let me subtract pi over 12. That's going to shift me to the left, pi over 12. Okay, let's grab this and let's paste this in. So starting with sine of x, vertically stretched by a factor of 6. So that matches, that matches. This says vertically shrink, so you can get rid of that. Vertically shrink, and this says vertically stretch. So these are good. So 1, 2, and 3. Those are what we're working with now. Then going to x, it says multiply by a third. So that's going to give me a horizontal shrink by a factor of a third. You really can't see this here because it's covered up, but that's what it says. So horizontally shrink by a factor of a third. This one says horizontally shrink by a factor of a third. This one says horizontally stretch by a factor of 3. So this one is out. Okay, the next thing is we're subtracting away pi over 12. Again, this is in terms of x. So that means we're going to shift to the left by pi over 12. So this one says shift left pi over 12. This one says shift right pi over 12. So get rid of this. And then lastly, you have and shift down 5. That's coming from this subtract away 5 here listed under y. So let me get rid of all of this. We know what we're looking for now. So this is the one we want. We would say starting with sine of x, vertically stretch by a factor of 6, horizontally shrink by a factor of a third, shift left pi over 12, and shift down 5. All right, let's take a look at question 12. So it says find the transformations required to obtain the graph starting with a basic trig function. So we have f of x is equal to 1/7, and then cotangent of, you're going to pull out a 4. So inside you would have x plus. Again, this 7 pi over 6, you would multiply that by a fourth to undo the multiplication by 4. So that would give you 7 pi over 24. Let's write that in, close that down, close this down. Then you have minus 4 there. Let me just take this to the next page. Okay, so again, you have y, and then you have x. So for y, you have this 1/7 that's multiplying this cotangent guy here. So let me put multiply by 1/7. So you could say it's a vertical shrink by a factor of a 7th, or you could say a vertical compression by a factor of 7. Again, you're just taking the y coordinate and either dividing it by 7 or multiplying it by a 7th. Then this minus 4 out here, that's shifting you down by 4. So let me put subtract 4. In terms of x, again, this is 1 and this is 2. How do I undo multiplication by 4? Well, I'm going to multiply by 1/4. And so that's going to give me a horizontal compression by a factor of 4, or again, you could say a horizontal shrink by a factor of a fourth. And then coming to the inside part, to undo the addition of 7 pi over 24, we want to subtract 7 pi over 24. So this right here is going to give me a shift left by 7 pi over 24. All right, so starting with cotangent of x, vertically shrink by a factor of a 7th. So you have that here. This one says vertically stretch, get rid of that. Vertically stretch, get rid of that. Vertically shrink by a factor of 1/7, and then vertically shrink by a factor of 1/7. Going on to x, you have multiply by a fourth. Again, that's going to give you a horizontal shrink by a factor of a fourth. So here it says horizontally shrink by a factor of a fourth. And then coming down here, horizontally shrink by a factor of a fourth. This one says horizontally stretch, so you can get rid of that. So then the next thing is, under x, we have subtract 7 pi over 24. That's going to go to the left, 7 pi over 24. This says shift right 7 pi over 24, so this is out. So we're left with this one. This one does say shift left 7 pi over 24. And again, coming back to y, you have this subtract away 4 here. That's this part right there. That's going to shift this down by 4. So here it says and shift down 4. So this is the one that you want. So let me erase this. And we'll just say that starting with cotangent of x, vertically shrink by a factor of 1/7, horizontally shrink by a factor of 1/4, shift left 7 pi over 24, and shift down 4. All right, let's take a look at the quiz. For the first question, we're asked to use the fundamental identities to determine which is true. And we are given that the cotangent of theta is equal to the negative of the square root of 15 over 15. And also that the cosine of theta is greater than 0 or positive. So if this cotangent is negative, which is going to be true in quadrants 2 or 4, and cosine is positive, which is true in quadrants 1 and 4, well, then I know I'm in quadrant 4. So you can say that theta, so theta is in quadrant 4. Now we're asked to determine which of the following is true. So first off, if you want your tangent of theta, let me take this to a different page. I don't think this is going to fit. For the tangent of theta, I'll say this is the reciprocal of this. So the negative of 15 over the square root of 15. And so I would rationalize the denominator there. And I would say negative 15 times square root of 15 over, you have square root of 15 times square root of 15. Now, the square root of 15 times square root of 15 is 15. So essentially, this would cancel with this, and you'd be left with the negative of the square root of 15. Okay, let's get rid of this, and we'll say this is the negative of the square root of 15. And then if you wanted to find your sine of theta or your cosine of theta, you could come to your little identities handout, and you have one with tangent here, and you have one with cotangent here, so just use one of those. And so tangent squared theta plus 1 is secant squared theta. So let's write tangent squared theta plus 1 is equal to secant squared theta. For the tangent of theta, I'm going to plug in the negative of the square root of 15, and that's going to be squared, so plus 1 equals secant squared theta. Let me just get rid of this step right here. We don't need it. So if I square the negative of the square root of 15, I'm just going to get 15, right? So get rid of this. We'll say this is 15 right here. 15 plus 1 is 16. And then if I use my square root property, we have the secant of theta is equal to, again, because we're in quadrant 4, secant is positive, so I want the principal square root of 16, which is going to be 4. So the secant of theta is going to be 4. Let me write that here. And that means my cosine of theta is the reciprocal of this guy right here, which is going to be 1/4. Okay, so if you want the sine of theta and your cosecant of theta, well, for the sine of theta, you could just use the fact that, again, sine squared theta plus cosine squared theta equals 1. So coming down here, I'll say that cosine squared theta, so 1/4, I'm just going to plug that in for cosine of theta, and I'm going to square that, plus sine squared theta equals 1. So if I square 1/4, I'm going to get 1/16. So this is 1 over 16 plus sine squared theta is equal to 1. Let me get rid of this so I have enough room to work. And I'll basically say here that sine squared theta is equal to, I'm going to subtract 1 over 16 away from each side of the equation. So I'm going to write 1 as 16 over 16 so I have a common denominator, and then minus this 1 over 16. Let me get rid of this. So 16 minus 1 is 15, so 15 over the common denominator of 16. Now, we are in quadrant 4, and sine is negative. So if I use my square root property, the sine of theta is equal to the negative of the square root of 15 over 16, which equals the negative of your square root of 15 over the square root of 16 is 4. So the negative of the square root of 15 over 4, that's going to be my sine of theta. Let me write that here. So the negative of the square root of 15 over 4. And then for the cosecant of theta, again, just find the reciprocal of this. So the negative of 4 over the square root of 15. So times the square root of 15 over the square root of 15. And maybe I should make that a little bit cleaner. So this equals, you would have negative 4 times square root of 15 over 15. So put negative 4 times square root of 15 over 15. Okay, let me get rid of this. And I'm just going to paste this. I know there's a lot of stuff everywhere. And I'm just going to go through things. And I know some of this is not easy to see. So the sine of theta here listed does not match this sine of theta. So let's get rid of that. That's not going to work. Then the cosine of theta is 1/4. So that does work. Let's just make sure nothing else is going to match here. Tangent of theta, that doesn't match, right? This is square root of 15. This is the negative square root of 15. So that doesn't work. And then you have your cosecant of theta. That's given as 4. So that's not a match. And then your secant of theta, that's not a match either. So let's just get rid of all of this. And so this is the answer we're looking for. We're just trying to figure out which one was true. And it's going to be this one. The cosine of theta is equal to 1/4. All right, let's take a look at question 2 now. So again, we want to use the fundamental identities to determine which is true. We're going to be given that the tangent of theta is equal to 4 times square root of 6 over 5. And then also, we are told that the cosine of theta is less than 0. So if cosine is negative and tangent is positive, that means we're in quadrant 3, right? Tangent is going to be positive in quadrants 1 and 3, and cosine is going to be negative in quadrants 2 and 3. So the overlap is going to be in quadrant 3. So let me grab this real quick. We'll just come down here, and maybe I'll just put up here that theta is in quadrant 3, so we don't forget. All right, now thinking about the cotangent of theta. So the cotangent of theta, again, just find the reciprocal of this. So this is 5 over 4 times square root of 6. I need to rationalize the denominator here. So times the square root of 6 over the square root of 6. So really you would just have 5 times square root of 6. Let me just write that up here. And then in your denominator, square root of 6 times square root of 6 is 6. And 4 times 6 would be 24. So let's write that down there. So your cotangent of theta is going to be 5 times square root of 6 over 24. All right, now in terms of finding sine or cosine, whichever one you want to do, going back to the little handout, if we come down here to the Pythagorean identities, if you want to work with tangent or you want to work with cotangent, either way, I'm just going to take tangent squared theta plus 1 is equal to secant squared theta. So let's look at tangent squared theta plus 1 is equal to secant squared theta. So for the tangent of theta, it's 4 times square root of 6 over 5. So this is 4 times square root of 6 over 5. And then don't forget to square this. So let's come down here. If I do 4 squared, that's going to be 16. And then times the square root of 6 squared is going to be 6. And this is over 5 squared is going to be 25. So nothing's going to cancel. So we would just do 16 times 6, which is 96. Over 25. So this is 96 over 25 plus, instead of 1, I'll write this with a common denominator. So I'll just say it's 25 over 25. And this equals our secant squared theta. Okay, so 96 plus 25 is 121. So let me actually flip the order here. I'll say that secant squared theta is equal to, as I just said, 96 plus 25 is 121. This is over the common denominator of 25. Now, we said we were in quadrant 3. In quadrant 3, secant and also cosine, they're both going to be negative. So what I want here is the negative square root. So I would say the secant of theta is equal to the negative square root of 121 over 25. So this is equal to negative, the square root of 121 is 11, and the square root of 25 is 5. So this is negative 11 fifths. All right, let me get rid of this, and I'll just say the secant of theta is negative 11 fifths. All right, for the cosine of theta, I'll just find the reciprocal of this. So this would be negative 5 over 11. And now I just need my sine of theta, and I need my cosecant of theta. Let's just use the sine squared theta plus cosine squared theta equals 1. I think we all know that at this point, and it's pretty easy to work with. Let me scroll down here just a little bit. So we have sine squared theta. Let me say this is equal to 1 minus cosine squared theta, just a different form. I'm going to plug in for cosine of theta, that's negative 5 over 11. So negative 5 over 11, and just square this. So this would end up giving me negative 5 squared is 25, and then 11 squared is 121. So this is 25 over 121. Let's write this 1 as 121 over 121, and we're subtracting this away, this 25 over 121. So 121 minus 25, that's going to be 96. So this would be 96 over 121. And because we're in quadrant 3, we know that sine and also cosecant, they're going to be negative. So I want my negative square root here of this 96 over 121. So this one's a little bit more tricky because 96 is not a perfect square. So let's say the negative of the square root of 96, and I'll break that up in a moment, over the square root of 121, we know that's 11. So for 96, we know that's 6 times 16. So let's say the negative of the square root of 16 times the square root of 6 over 11. And so the square root of 16 is 4. Let me just do this in line. So you'd end up with negative 4 times square root of 6 over 11. Let me get rid of all this. Okay, so let me just drag this up here like this. And you can maybe bring this down here a little bit for formatting. I guess it doesn't really matter. For the cosecant of theta, we're just going to find the reciprocal of this. So negative 11 over 4 times square root of 6. And again, you want to rationalize the denominator. So this is times the square root of 6. And then this is times the square root of 6. Square root of 6 times square root of 6 is 6. So this would be 4 times 6 down here, which is 24. So basically what you'd have is negative, you'd have 11 times square root of 6 over this 24. Okay, so let's copy all this. And I'm just going to come back up here. And I know this is going to be extremely difficult to read with everything being laid over everything else. We're just going to go through and see what's true. It's only going to be one of them. So we have the sine of theta is 6 over 11. So that's definitely not true. Let's get rid of that right there. Then we see that the cosine of theta, I know you probably can't read this, so let me actually move this out of the way. So this says the cosine of theta is equal to the negative of the square root of 11 over 5. That's not what we got. So let's get rid of that. And then we have the cosecant of theta is equal to the negative of 14 times square root of 3 over 24. So that's not what we got there. We've got the secant of theta is equal to the negative of 11 times square root of 6 over 24. That's not what we have there. And then we were given this one, so you can actually get rid of that. We're just left with this one. So cotangent of theta is 5 times square root of 6 over 24, and that's what we have, right? Cotangent of theta is 5 times square root of 6 over 24. So that's the correct solution here. Again, when we're just trying to figure out which of these guys is true, it's only going to be this one. All right, let's take a look at question 3 now. So we want to use the fundamental identities to determine which is true. So we have the cotangent of theta is equal to the negative of 7 times square root of 30. This is over 60. We're also told that the sine of theta is greater than 0 or positive. So for cotangent, remember it's negative in quadrants 2 and 4. Now sine is positive in quadrants 1 and 2. So this tells me that theta is in quadrant 2. So let me write here that theta is in quadrant 2. Okay, so for the tangent of theta, again, just take the reciprocal of this. So negative, you'll have 60 over 7 times square root of 30. And then you'll multiply by the square root of 30 over the square root of 30. So if you do the square root of 30 times the square root of 30, you're going to get 30. So this would be 30 down here. And if you have 60 divided by 30, that's 2. So let's get rid of this and just put a 2 here. So this is the negative of 2 times the square root of 30 over 7. So that's going to be your tangent of theta. You can use this guy right here or this guy right here. So I'm just going to use tangent squared theta plus 1 equals secant squared theta, or I'll rearrange that and say secant squared theta is equal to tangent squared theta plus 1. Okay, so for tangent squared theta, I'm just going to plug in this negative 2 times square root of 30 over 7, and we're going to square that guy. So let's write secant squared theta is equal to, if I square negative 2, I get positive 4. If I square the square root of 30, I get 30. And if I square 7, I get 49. So this is going to end up being 4 times 30, which is 120 over 49. So this is 120 over 49. Nothing's going to cancel there because 49 is 7 times 7. So then plus for 1, I'm going to write that as 49 over 49. So 120 plus 49 is 169. So this would be 169 over 49. And again, if we're going to be in quadrant 2, then our secant is going to be negative. So we'll say that the secant of theta is equal to the negative square root of 169 over 49, which is equal to the negative of the square root of 169, which is 13, over the square root of 49, which is 7. So negative 13 over 7. And let me write this over here. We'll say the secant of theta is equal to negative 13 over 7. So that tells me my cosine of theta is equal to negative 7 over 13. Okay, let's just find the sine of theta using our sine squared theta plus cosine squared theta equals 1. So let's say that our sine squared theta is equal to, I'm going to have 1 minus cosine squared theta, so just a different form, and that's just me subtracting cosine squared theta away from each side. You're just going to plug in for cosine of theta, which is negative 7 over 13, and I'm going to square that. So this would give me 49 over 169. So 49 over 169, and I would write this as 169 over 169 minus 49 over 169. 169 minus 49, that's 120. So this would be 120 over 169. Now, because I'm in quadrant 2, I know that sine is going to be positive. So I could say the sine of theta is equal to the principal square root of 120 over 169. So this is going to be the square root of 120 over the square root of 169 is 13. Now, for this one, I would just break this up. And I know 120 is divisible by 4, right? So it would be 30 times 4. So 4 times 30. Now 30 is going to be what? It's 6 times 5, and 6 is 2 times 3. So you really can't do anything else there other than say the square root of 4 is 2. So you can say that this is 2 times the square root of 30 over 13. So that's going to be for my sine of theta. Let me get rid of this and say my sine of theta is 2 times square root of 30 over 13. And of course, for the cosecant of theta, just find the reciprocal. So 13 over 2 times square root of 30. I'll multiply by the square root of 30 over the square root of 30. And so for this one, basically square root of 30 times square root of 30 is 30, and 30 times 2 is 60. So this would be 60 down here, and up here this is 13 times square root of 30. So 13 times square root of 30. Okay, let's slide back up here, and I'm just going to copy all this. So I know this is hard to read, but the sine of theta here says it's equal to 2 times square root of 15 over 13. That's not what we get for sine of theta. So let's get rid of this one right here. And then for cosine of theta, this is negative 7 over 13. Here it says it's going to be negative 13 over 7. So this is wrong. Let's get rid of this. And then for the tangent of theta, it says it should be 2 times square root of 30 over 7, but it's negative 2 times square root of 30 over 7. So let's get rid of this. That's not right. And then for cosecant of theta, it says it should be 11 times square root of 30 over 60. That's not what we have. We have 13 times square root of 30 over 60. And lastly, we have for the secant of theta, we have the negative of 13 over 7. So that's what we have here. So this is the one we want to select. Again, for this problem that's asking us to use the fundamental identities to determine which is true, what's going to be the one where the secant of theta is equal to the negative of 13 over 7. All right, let's take a look at question 4. So we're asked to begin by writing each in terms of sine and cosine. Once this is done, simplify so that no quotients appear in the final expression, and all functions are of theta only. We have a note here that your final expression may not contain sine or cosine. So I'm just going to write this. So cosecant of theta over cotangent of negative theta. So let's see what we can do here. Now the first thing is to write everything in terms of sine and cosine. So for cosecant of theta, we know this is 1 over this sine of theta. And let's go ahead and say this is over. For the cotangent of negative theta, remember the cotangent of theta, forget about the fact that's negative theta for right now, is going to be the cosine of theta over the sine of theta. Well, here it's the negative theta, so we'll just put cosine of negative theta over the sine of negative theta. So we know how to divide with fractions here. Take this guy here, so 1 over the sine of theta, and I'm going to multiply by the reciprocal of this. So you'd have the sine of a negative theta, and this is going to be in the way, so let me drag this down here, over this guy, so cosine of negative theta. Okay, let me slide down here just a little bit. We'll say this is equal to, so we know from the negative angle identities that the sine of negative theta is equal to negative sine of theta, and then the cosine of negative theta is equal to the cosine of theta. So coming back here, I'm just going to say this is 1 over the sine of theta times, again, I can just write this as the negative of the sine of theta over this guy right here. We would have just cosine of theta, right? The cosine of negative theta is just the cosine of theta. All right, so I can cancel this right here. Let me make this a little bit more clean. So this right here with this right here, and this is just a negative 1. So this just gives me negative 1 over the cosine of theta. Now, if I think about what I could do with this, I know that I don't want any quotients. It told me that in the instructions. So I know that 1 over the cosine of theta is the secant of theta. So let's say this is negative 1 times the secant of theta, which is just the negative of the secant of theta. So coming back, we have this guy right here, which is the negative of the secant of theta. All right, for question 5, we want to begin by writing each in terms of sine and cosine. Once this is done, simplify so that no quotients appear in the final expression and all functions are of theta only. Again, we want to note that your final expression may not contain sine or cosine. So let me write this 1 minus cosine of theta times this 1 plus the secant of theta. So this one's a little bit tricky. Let's go ahead and grab this real quick. So the first step is to write things in terms of sine and cosine. So this has cosine, this has secant. So let's go ahead and say this is 1 minus the cosine of theta, and then times 1, I'll go ahead and say plus, you have 1 over the cosine of theta, right? So the secant of theta is 1 over the cosine of theta. All right, so I'm going to use FOIL here. So I'm going to start with the first terms. 1 times 1 would be 1 squared, or just 1. Then your outside, you have 1 times 1 over cosine of theta. So that's plus 1 over cosine of theta. Then your inside, or some people say the inner, you basically have a negative there. Cosine of theta times 1 is just cosine of theta. And then for the last, you have negative times positive, which is negative. And you'll have cosine of theta basically multiplied by 1 over cosine of theta. So cosine of theta over cosine of theta. Okay, so let's see what this is going to give us. Looks like it's kind of promising at this point. So this right here is going to be 1. So if you have 1 minus 1, that's 0, so that's gone. So what you have is 1 over the cosine of theta minus the cosine of theta. Okay, so I could write 1 over cosine of theta as the secant of theta. So let's go down here and say that this is the secant of theta minus the cosine of theta. So let's come back up, and we want this one right here. So the secant of theta minus the cosine of theta. All right, let's take a look at the quiz. For the first question, we're asked to choose the trigonometric expression that completes the identity. So the first guy we have here is tangent squared x over, we have cosine x times secant of x. Let me make this a little bit better. Now, immediately you should recognize that cosine of x times secant of x, that's 1. So what you can do is say that this right here is equal to the tangent squared x. You could put over 1 if you wanted to, but I'm just going to write tangent squared x. Now, if I look through here and just compare things, I'm thinking about, well, what could I do here? Well, I see that I have secant squared x minus 1. And if you come to your identities and you look at tangent squared theta, well, if you subtracted 1 away from each side there, it would be equal to secant squared theta minus 1. So coming back, I could say that this guy right here is equal to secant squared x minus 1. And so this is the guy we want to say. So really, the identity, if you wanted to write it out, you could say this is equal to your secant squared x minus 1. All right, let's take a look at question 2. So once again, we're asked to choose the trigonometric expression that completes the identity. We are given cotangent of x over cosine squared x plus sine squared x. Now you should immediately recognize that this right here, cosine squared x plus sine squared x, that's going to be 1. So really, this is just cotangent of x. So I can manipulate this and just write this as cosine of x over sine of x. And just looking through my choices, I don't really see that, but you do see cosecant of x over secant of x. So in other words, what I could do here is say that cosine of x is 1 over the secant of x. And if you have this as 1 over sine of x, that's really your cosecant of x. So that gets me to that cosecant of x over the secant of x. So it's going to be this guy right here. And again, you could erase all this if you wanted to and write it more cleanly just as an identity. And so I'll write this as the cosecant of x over the secant of x. All right, let's take a look at question 3. So again, we're asked to choose the trigonometric expression that completes the identity. We are given cosecant squared x plus secant squared x. Let me grab this real quick. And I'm just going to come over here and simplify. We'll go back up and look at the choices in a moment. So the first thing I would do here is write this as 1 over sine squared x plus 1 over cosine squared x. You would want to get a common denominator there. So basically, I would multiply this guy by cosine squared x over cosine squared x. So I would say this is cosine squared x over sine squared x times cosine squared x. Then plus, over here I would multiply by sine squared x over sine squared x. So this would give me, let me slide this down a little bit so it fits. This would give me sine squared x over your sine squared x times cosine squared x. And then I have a common denominator now. So let's say that this is cosine squared x plus sine squared x over your sine squared x times cosine squared x. Now, we know that cosine squared x plus sine squared x is 1. So let's replace this and say this is 1 over, we'll have sine squared x times cosine squared x. I'm just going to grab this real quick, and I'm going to paste this in here and just see what we can do to manipulate this. Let me write cosecant squared x plus secant squared x. And let me slide this part down here. and say this is equal to this. And then from here, let's see what we can get this to be equal to. So looking through my choices, it looks like I want this one, right? So this is what it's going to be. And it's easy to get there because 1 over sine squared x can be written as cosecant squared x. And this would be over your cosine squared x. So let me actually get rid of this part right here and drag this up here. So that would be us completing the identity. So the cosecant squared x plus secant squared x would be equal to your cosecant squared x over cosine squared x. All right, let's take a look at question 4. So again, we want to choose the trigonometric expression that completes the identity. So we have cosecant squared x plus secant squared x over tangent squared x. So let me grab this real quick and see what we can do with it. So the first thing is I'm going to write this 1 over tangent squared x as cotangent squared x. So essentially I'm going to have cotangent squared x out here, and it's multiplying this quantity cosecant squared x plus secant squared x. And I'm just doing that because something's going to cancel later on. Now, you didn't have to do that. You could have left this guy here, but I find it a little bit more convenient to write it like this. So let me come down here a little bit, and I put my equals here. So maybe I'll just put my equals here, and I'll delete it from here, and then I'll just keep going down like this. So what I'll say here is that the cosecant squared x can be written as 1 over sine squared x. So let me write the cotangent squared x times this quantity, 1 over sine squared x, and then plus secant squared x, that's 1 over cosine squared x. And for this one, now what I'm going to do is replace cotangent squared x with cosine squared x over sine squared x. Now, you could distribute this now if you want to, or you could wait. It's really not going to matter, so it's personal preference. I think maybe I will just wait and combine these guys first, and then I'll multiply by this in the end. So let's put equals here. And to get a common denominator, you would multiply this by cosine squared x over cosine squared x. Let me write this out first. So cosine squared x over sine squared x. And this guy, again, I'm multiplying by cosine squared x over cosine squared x. So this is cosine squared x over sine squared x times cosine squared x. And then you're going to have plus. Here I'd multiply by sine squared x over sine squared x. So you're going to have sine squared x over, you have sine squared x times cosine squared x. So once again, you have the situation where this plus this is going to give you 1. So now you're going to have cosine squared x over sine squared x. And then this would be multiplied by, this would be 1 over that common denominator of sine squared x times cosine squared x. And we're going to see that this is going to cancel with this. So basically at this point, you have 1 over, you have sine squared x times sine squared x. So that is sine, we're going to put to the 4th power here, x. So basically you're going to see, let me just grab this real quick. You don't have exactly this, but you do have this, right? So the cosecant, again, this is raised to the 4th power here of x. That's going to match this 1 over sine to the 4th power x. So let's go ahead and say that this guy right here, I'm just going to write it out. So cosecant squared x plus, let me slide this down a little bit here. You have your secant squared x. This is over your tangent squared x. This would be equal to, I'm going to say this is cosecant. We have going to the 4th power of x. So it's going to be this guy right there. All right, let's take a look at question 5. So we want to choose the trigonometric expression that completes the identity. And here we're going to have the cosine of, looks like negative x over, you have 1 plus your sine of negative x. Okay, so whenever you see something like the cosine of negative x or the sine of negative x, remember you can use these negative angle identities, which again, some people will call even odd identities. So the sine of negative theta is equal to the negative of the sine of theta, and then the cosine of negative theta is equal to the cosine of theta. So go ahead and make that replacement first. Let me put equals here. I'm actually just going to go to a different sheet so we don't run out of room. So let me put here that this is the cosine of x. Again, cosine of negative x is equal to cosine of x over, instead of 1 plus the sine of negative x, it would be 1 minus the sine of x. From here, let me just copy this. Cosine of x over 1 minus the sine of x. Whenever you see 1 minus the sine of x or 1 plus the sine of x and you're verifying a trigonometric identity, generally speaking, but not always, but most of the time, you want to basically multiply by the conjugate. So remember, a minus b multiplied by a plus b, those are conjugates, you get that a squared plus b squared. So that's the formula we want. So what we're going to do here is multiply this by 1 plus sine of x over 1 plus the sine of x. And let me wrap this so this is crystal clear what's going on. And we'll say that we have our cosine of x times this 1 plus the sine of x over, you have this 1 times 1, which would be 1 squared or 1, minus sine squared x. So sine squared x. So remember that pattern. This guy squared minus this guy squared. You don't need to FOIL it out because the middle two are going to drop out. So 1 minus sine squared x, if you go back, you can replace that with cosine squared x, right? So if you did sine squared theta plus cosine squared theta equals 1, if you subtract sine squared theta away from each side, you get cosine squared theta is equal to 1 minus sine squared theta. Well, if you have 1 minus sine squared x, you can just replace that with cosine squared x. So we'll say this is equal to cosine of x times the quantity 1 plus the sine of x. So this is over. Again, I'm going to replace this with cosine squared x. This is going to cancel with one of these. And so now what I have is 1 plus the sine of x over the cosine of x. So this is 1 plus the sine of x over the cosine of x. So at this point, let's stop and let's see what we have. Just going to come back up here and think about what we have. So right now I don't have a match with anything. Let's see. We have this sine of x, which matches this part right here. And then I have times cotangent of x. So that's not actually going to work. Then I have sine squared x. That's not going to work. Negative tangent squared x. That's not going to work. 1 plus cotangent squared x. That's not going to work. It's going to have to be this one, actually, without even checking it. And let's just go through and prove that. So this guy would be equal to, let me slide this over. This guy would be equal to 1 over cosine of x, which we know is the secant of x. And then plus you have the sine of x over the cosine of x. So this right here is the secant of x. And then plus sine of x over cosine of x is the tangent of x. So that's the guy we're looking for. Let me get rid of this scratch work here. And I'm just going to write this so it's crystal clear. We started with the cosine of negative x over 1 plus the sine of negative x. We'll say that's equal to this expression here, which is going to be your secant of x. Let me make this a little bit better here. I'll just format it better. So the secant of x plus the tangent of x. So that's going to be our answer for this one. All right, let's take a look at the quiz. For the first question, we're asked to find the exact value. And we're given the cosine of negative pi over 12. Let me grab this actually, and we'll come to this sheet here. So the first thing is I'm going to use my negative angle identity for cosine to rewrite this as the cosine of pi over 12. Remember, the cosine of negative theta is the same as the cosine of theta. So that's the first thing. The second thing is, if you're uncomfortable breaking this up using radians because of the fractions, just convert it over into degrees and then convert it back. So if you have pi over 12 and you want to convert that over to degrees, you multiply this by 180 degrees over pi. And then this pi is going to cancel with this pi. So 180 divided by 12 is 15. So this is 15 degrees. So what I'm going to do is break this up into, let's say, 45 degrees minus 30 degrees. So that's what I'm going to do. You could do it a different way if you want to. So let's say this is going to be the cosine of, for 45 degrees, if you're working with radians, this is going to be pi over 4. Then minus, if you have 30 degrees, in terms of radians, that's going to be pi over 6. So if you get lost in this stuff, you can always just pull up your little unit circle handout and reference that. So now what I would do is just use my difference identity for cosine. Pretty simple to remember that. So it's the cosine of the first guy times the cosine of the second guy. So the cosine of pi over 4 times the cosine of pi over 6. Remember, when you're working with the cosine identity for either the sum or the difference, you always want the opposite sign. So here it's a minus, so I want a plus. Then you go sine of the first guy, so pi over 4. let me make this 4 a little bit better here, times the sine of the second guy, so pi over 6. So I'm not going to pull up the unit circle. I think we know this stuff because it's in the first quadrant. If you don't, you can just pause the video and pull up your unit circle. But I'll go ahead and just say that cosine of pi over 4, we know that's, again, 45 degrees, and that's going to be the square root of 2 over 2. And then times the cosine of pi over 6, again, that's 30 degrees, so this is the square root of 3 over 2. Then plus the sine of pi over 4, that's going to be square root of 2 over 2. And then times the sine of pi over 6, we know the sine of 30 degrees is going to be 1/2. Okay, so now that we have that, let's just go through and crank out the arithmetic. Square root of 2 times square root of 3 is the square root of 6. This is over 2 times 2, which is 4. Then plus square root of 2 times 1 is the square root of 2. This is over 2 times 2, which is 4. So let's just write this as the square root of 6 plus the square root of 2 over the common denominator of 4. Okay, coming back, I'm going to want to select this answer. So the square root of 6 plus the square root of 2 over 4. Okay, let's look at question 2. So here we want to find the exact value. So we have the cosine of 4 pi over 9 times the cosine of 7 pi over 36. And here you have a plus. So let's note that. And then you have the sine of this 4 pi over 9, and then times the sine of this 7 pi over 36. Now notice this angle right here and this angle right here are the same. This angle right here and this angle right here are the same. And you have this plus sign here. So going in reverse, again, because you have a plus, you want the cosine difference identity. Okay, so I want to say that this is the cosine of, take the first angle, which is 4 pi over 9. Again, because this is a plus, I want a minus, and then take your second angle. So this is 7 pi over 36. Okay, so from here, it's not that bad. You would just want to get a common denominator. Let me maybe move this down a little bit, and I drug the 4 with me. Let me put that there. And I'm just going to multiply this by, let's see, I need 4 over 4 to get a common denominator. So 4 times 4 would be 16. So let's say this is 16 pi over 36, and 16 pi minus 7 pi is 9 pi. So this is going to be the cosine of 9 pi over 36, which is the cosine of, we can reduce this guy because each is divisible by 9. 9 divided by 9 is 1. 36 divided by 9 is 4. So basically this is the cosine of pi over 4, or the cosine of 45 degrees, which is square root of 2 over 2. So let me get rid of all this, and I'll just select my answer of the square root of 2 over 2. Okay, let's take a look at question 3. So here we're asked to simplify, and we have the cosine of x times the cosine of 6x, then minus the sine of x times the sine of 6x. So what you're meant to do here is, again, realize that you have basically the cosine sum identity, but in reverse, right? So we could rewrite this and say this is the cosine of the first guy. Let me make this s a little bit smaller here. The first guy is x, and then because this is a minus, I want a plus, right? So again, this is the cosine sum identity. And then you just want your second guy, which is 6x. Again, if you went through the formula, you'd be right back to that. So you're just going in reverse. So now I can just simplify this. This is the cosine of what? X plus 6x is 7x. So it's just the cosine of 7x. So this guy right there. All right, let's take a look at question 4. So here we have the cosine of s. Let me write this out. So the cosine of s is equal to the square root, and I messed that up. So the square root of 2 over 4. And then we have the sine of t is equal to the negative of the square root of 5 over 6. Now we're told that s and t are both in quadrant 4. So we want to find the cosine of s plus t. And I hate putting a plus next to a t. So let me circle this so it's clear that that's a plus. Let me actually grab all this. These problems can get very, very tedious very quickly. So let me just write out the cosine of t. We're going to need that. And let's write out the sine of s. And actually, I'm just going to switch the position of this. Let me just erase this and write the sine of s equals, and let me drag this up here. So you can make a sketch if you want, but I prefer to just work with the Pythagorean identity of cosine squared theta plus sine squared theta equals 1. So that's how you're going to get your missing guy in each case. So make sure you're working with the same thing. So in other words, if you want the sine of s, you need to work with the cosine of s. If you want the cosine of t, you need to work with the sine of t. So let's start with this first one. And actually, I'm going to move this to another page. So I'm going to come down here and say we want the cosine of s plus t. Let me circle this again so nobody's lost. And let me just expand this now. This is going to be the cosine of s times the cosine of t, and then minus, again, always opposite sign, the sine of s times the sine of t. And I'll just bring everything down once we have it. So if I want the sine of s, let's say we would have sine squared s is equal to 1 minus cosine squared s. Now I know what the cosine of s is. It's the square root of 2 over 4. So I'm going to plug in here the square root of 2 over 4, but you have to be careful. You have to square this. A lot of people forget to square it, and then they get the wrong answer. So this, if I squared the square root of 2, I would get 2. If I squared 4, I would get 16. So this would be 2 over 16, which you could really write as 1 over 8, right? Each is divisible by 2. So this is 1 over 8 if you simplify. Now for 1, you could write that as 8 over 8, so you have a common denominator. So this becomes 8 minus 1, which is 7, over the common denominator of 8. So sine squared s is 7 over 8, or 7/8 if you want to say it that way. Now in order to get sine of s, I need to use my square root property. Remember, we said that we were in quadrant 4. Now for quadrant 4, sine is negative. So you want to choose the negative square root. So the negative, let's go square root of 7 over square root of 8. And this is going to be a little bit of extra work here because 8 is not a perfect square. So let's go ahead and say that this is what? This is the square root of 2 times the square root of 4, and the square root of 4 is 2. So this is 2 times the square root of 2. So let me multiply this by the square root of 2 over the square root of 2. And so you would have the negative of the square root of 7 times 2, which is 14, over, you have 2 times square root of 2 times square root of 2. Square root of 2 times square root of 2 is 2. 2 times 2 is 4. So the negative of the square root of 14 over 4. Let's put that up here. So the negative of the square root of 14 over 4. And then for the cosine of t, just going to use a similar strategy. So cosine squared t is equal to 1 minus sine squared t. So I'm just going to plug in this negative square root of 5 over 6 and then square it. So this is my sine squared t. So for this one, the negative goes away. Squaring a negative gives me a positive. Square root of 5 squared is 5. 6 squared is 36. So this is 5 over 36 here. And this right here I can write as 36 over 36, so I get a common denominator. 36 minus 5 is 31, so this is 31 over 36. 31 over 36. Now I'm in quadrant 4, and in quadrant 4, cosine is positive. So we would say the cosine of t is equal to the principal square root of 31 over the principal square root of 36, which is just going to be the square root of 31 over square root of 36 is 6. So let me write the square root of 31 over 6. Okay, let me paste this in here. And so I'm just going to erase this and bring this over here and just kind of arrow to this. We can say this equals this. And then I'm going to arrow to this, get rid of this, and drag this up here. Let me put a multiplication symbol there. And let me get rid of this and put a minus there. So this is a negative and this is a minus in the formula. So be very, very careful. You're going to have a minus and then a negative value here. So let me move this over here. You can even wrap this in parentheses if you want so that you don't make a sign mistake. I think that's something that I do personally sometimes when it gets a little confusing like that. Then for this one, let me drag this up here and I'm just going to close the parentheses down. Okay, get rid of that. And we're just going to do some basic arithmetic. So let's come down here. The first one, we've got a positive and a positive. So square root of 2 times square root of 31 would be the square root of 62 over 4 times 6, which is 24. Okay, nothing else I can do there. Then you have minus. Inside of here, you have negative times negative, which is a positive. So you would do square root of 14 times square root of 5, which would be the square root of 70 over 4 times 6, which is 24. So here you have the square root of 62 minus the square root of 70. And I think the answer is reversed. So you could write it as the negative of the square root of 70 plus the square root of 62, or you could flip it around and say the square root of 62 minus the square root of 70. Whatever you want to do, it's the same thing. Then over the common denominator of 24. So let's grab this. And coming back up here, let's say we want this answer right here. So for the cosine of s plus t, you want the negative of the square root of 70 plus the square root of 62, and this is over 24. All right, for question 5, we're asked to complete the identity. So we have 1 plus the cosine of 2x minus cosine squared x. Now I have a hint. 2x, which is from that guy right there, is x plus x. So what I would do is write this as 1 plus the cosine of x plus x, and then minus cosine squared x. Let me grab this right here. I'm going to cut this away. We'll come back up in a moment. I'm just going to paste this in and see what we can get. So let me put equals here. This is 1 plus. Again, if you use your formula, this is the cosine of x times the cosine of x again. And then because this is a plus right here, this becomes a minus. Your sine of x times your sine of x. And then minus your cosine squared x. Well, I want you to notice that cosine of x times cosine of x is cosine squared x. So you can make this cosine squared x. You can make this sine squared x. But let me slide this down so it all fits. And I'll just bring this up here. You have cosine squared x minus cosine squared x. So this is going to cancel with this. Those are gone. So what you have now is 1 minus sine squared x. And remember, that's a different form of sine squared theta plus cosine squared theta equals 1. So 1 minus sine squared x is actually equal to cosine squared x. So we'll say this is cosine squared x. We'll go back up. To complete this, I'll put cosine squared x. And just looking through, we want that guy right there. All right, let's take a look at the quiz. For the first question, we're asked to find the exact value. And we are given the tangent of 5 pi over 12. So let's grab this. And when you work on this type of problem with tangent, it does take a lot longer because there's just extra calculations. So the first thing is I'm going to either use my sum identity for tangent or my difference identity for tangent. I need to think about the angle first and just grab whatever makes sense. So the first thing is it's hard to break this up using fractions. So you might need to convert it over to degree mode. So I'm just going to do that so everybody can follow along. So 5 pi over 12 times 180 degrees over pi. And this is going to cancel. 180 divided by 12 is 15. 15 times 5 is going to be 75. So this is 75 degrees. Now, one way you could do this is you could use the tangent sum identity, and you could break this up into 45 degrees, which is on the unit circle, plus 30 degrees, which is on the unit circle. So you could say that this is the tangent of, and I'm going to use radians here. So 45 degrees would be pi over 4. And then plus 30 degrees would be pi over 6. Okay, so let's get rid of this. And I'm just going to go through and set up my little formula now. And so I'll say this is equal to, again, if this is a plus here, you're going to go tangent of the first guy, so it's pi over 4, plus the tangent of the second guy, so it's pi over 6. So again, this sign matches this sign. Then this is over 1, and then the sign is different. So if this is a plus, this would be a minus. So you're going to take this guy times this guy. So the tangent of pi over 4 times the tangent of pi over 6. Okay, let's put equals here. Let's come down, and I'm just going to go to a new page. Now, on the unit circle, if you're using this, if you go to pi over 4 or pi over 6, you only have the sine value and the cosine value given to you, okay? You need to still calculate the tangent value. Now, for the tangent of pi over 4, this is really easy to remember. It's going to be 1. That's because your sine of pi over 4 is square root of 2 over 2, and your cosine of pi over 4 is square root of 2 over 2. So the same non-zero number divided by itself would give you 1. So this one's easy to remember. The other one, the tangent of pi over 6, you have to do a little bit of work. So this is the sine of pi over 6 divided by the cosine of pi over 6. And for this one, the sine of pi over 6, or the sine of 30 degrees, is a half. And let's multiply by the reciprocal of this guy. So the cosine of pi over 6, or the cosine of 30 degrees, is square root of 3 over 2. But again, I want the reciprocal because I'm dividing here. And so I'm going to go 2 over the square root of 3. And so this right here is going to cancel, and I get 1 over the square root of 3. So here I would need to rationalize the denominator. So let's say this is the square root of 3 over 3, right? So that's just me multiplying by the square root of 3 over the square root of 3, so I can rationalize the denominator. So let me get rid of this and drag this up here. And let me copy these. And let's just paste this in here. So everywhere we see tangent of pi over 4, I'm just going to plug in a 1. So there, and also there. Now we know 1 times anything is itself, so you can actually get rid of it from there. Now let me get rid of this. We don't need this anymore. Then where we see tangent of pi over 6, I'm going to put square root of 3 over 3. So this is square root of 3 over 3. And then this is square root of 3 over 3. Now what I'm going to do from here is multiply the numerator and denominator of the complex fraction by 3. And that's just going to clear the denominator. So that's going to get rid of this guy right here. And also it's going to get rid of this guy right here. So 1 times 3 is 3. Then plus, again, the denominator would cancel there. So you just have the square root of 3. This is over. 3 times 1 is 3, and then minus. Again, the denominator will cancel here, so you have square root of 3. Okay, so you see that these problems are quite a bit of work. Let me actually move this down here a little bit. What I'm going to do is multiply by the conjugate of the denominator. Remember, if you have two terms like this, so 3 minus square root of 3, well, you can multiply by 3 plus the square root of 3 over 3 plus the square root of 3. And what that is going to do is give us that pattern of a minus b, that quantity, times the quantity a plus b. So you say a squared minus b squared, you use your formula. Now in the numerator, you can use your a plus b quantity squared formula. So the first guy squared, 3 squared is 9. Then plus 2 times the first guy times the second guy. So 2 times 3 is 6, and then times the square root of 3. And then lastly, plus this guy squared, so square root of 3 squared is 3. Now 9 plus 3 would be 12. So let's put 12 out in front. So 12 plus 6 times square root of 3. This is over. Again, down here you can use your a squared minus b squared. So the first guy squared is 9. Then minus square root of 3 squared is 3. So this would be 6. Now, you can further simplify this by pulling out a 6 from the numerator. So we'll say this is 6 times. You'll have 2 plus square root of 3 over 6. And then lastly, we'll cancel this common factor of 6 between the numerator and denominator. So this gives me 2 plus the square root of 3. So coming back up, I want to select this. So 2 plus the square root of 3. All right, let's take a look at question 2. So here we're asked to find the exact value. And we're given the tangent of 137 degrees minus the tangent of 17 degrees. This will be over 1 plus the tangent of 137 degrees times the tangent of 17 degrees. All right, so for this type of problem, again, I'm going to think about this sign right here and the fact that this angle and this angle is the same, this angle and this angle is the same. So this is my difference identity for tangent in reverse. So all I need to do is say this is the tangent of this guy right here, so this 137 degrees, then minus, again, this sign and this sign will match, this sign and this sign will be different, and then your second angle here, which is 17 degrees. So this right here would be the tangent of 137 degrees minus 17 degrees is 120 degrees. Now, thinking about this, the tangent of 120 degrees is going to be the sine of 120 degrees over the cosine of 120 degrees. Now, the sine of 120 degrees, again, if you're not using the unit circle, you have a 60-degree reference angle, okay? So the sine of 60 degrees is square root of 3. So square root of 3 over 2. In quadrant 2, where this angle lies, this 120 degrees, your sine value is going to be positive. So this is over the cosine of 120 degrees. So 60-degree reference angle. In quadrant 2, you're going to be negative, and the cosine of 60 degrees is a half. So this is negative 1/2 for the cosine of 120 degrees. So this would be equal to the square root of 3 over 2 times, take the reciprocal of this. So this is negative 2 over 1. And so this would cancel, and you basically get the negative of the square root of 3. So coming back up here, I want to select the negative of the square root of 3. All right, let's take a look at question 3. So here we're asked to complete the identity, and we have 1 minus the tangent of theta over 1 plus the tangent of theta. So for this one, it's pretty easy to just look through the choices. And immediately, if you look at this one right here, where you see that you have the tangent of pi over 4 and then minus theta like this. Let me wrap this for clarity. Let me actually grab this real quick and I'll prove that this works. So let me push this down here. And then basically what I'm going to do is go through and make this guy match this guy. So for this one, you would use your difference identity for tangent. So we would say this is the tangent of pi over 4, then minus the tangent of theta. Then this is over 1 plus the tangent of pi over 4 times the tangent of theta. Now we know the tangent of pi over 4, because we talked about it in a previous problem, is 1. So anywhere I see the tangent of pi over 4, I can replace it with 1. So let me come down here and put equals. This is 1 minus the tangent of theta. This is over 1 plus the tangent of theta. So we're done. So coming back up here, this is the guy that we want. So that would complete your identity. This 1 minus the tangent of theta over 1 plus the tangent of theta would be equal to your tangent of your pi over 4 minus theta. So that guy right there. All right, let's take a look at question 4. So here we're asked to complete the identity, and we are given the tangent of theta plus beta. And then minus, we have the tangent of beta, and this is over. We have 1 plus our tangent of theta plus beta, and then times the tangent of beta. Okay, let me grab this real quick. I think this one is pretty obvious in terms of what's going on. So let's come down here. And basically, we just have the difference identity for tangent in reverse, right? You have a minus here, you have a plus here. So I can say that this is the tangent of the first angle is theta plus beta. And then I'm going to subtract away the second angle is beta. Well, beta minus beta is 0. So this is just going to be the tangent of theta. So that's all it is. So coming back up here, it's just the tangent of theta. You could write this in like this. So this is the tangent of theta. All right, let's take a look at question 5. So we have find sine of theta plus beta, find tangent of theta plus beta, and then the quadrant of theta plus beta. And then we're given that the sine of theta, let me write this out here. So the sine of theta is equal to 2/3. And then we are given that the sine of beta is equal to negative 1/3. We're given that theta is in quadrant 2. So this guy's in quadrant 2. So the cosine value, I'm just going to say is going to be negative. And the tangent value will be negative, but we'll figure that out in a moment. Then over here, beta is in quadrant 4. So the cosine value will be positive. Okay, let me grab this. And let's get our cosine value in each case real fast. And then we'll calculate the tangent value. And then we can just plug into the formulas. So first and foremost, if the sine of theta is 2/3 and I'm in quadrant 2, well, I can just say cosine squared theta is equal to 1 minus your sine squared theta. So your sine of theta is 2/3, and you'd want to square that. So this would be 4/9. So this is 4/9, and this right here would be 9/9. So this would be 5/9. So we have 5/9. Okay, let me slide this down a little bit. So for the cosine of theta, I want the negative of, let's just do the square root of 5 over the square root of 9, which is the negative of the square root of 5 over 3. So let me slide this down a little bit so everything fits. Get rid of this comma here. So this is the negative of the square root of 5 over 3. Okay, let me get rid of this. You can calculate your tangent now if you want it, or you can wait till you're all done. It's really up to you. Let's just get it now. So the tangent of theta is equal to your sine value, which is 2/3, divided by your cosine value, which is negative square root of 5 over 3. To divide fractions, you multiply the first fraction by the reciprocal of the second. So I'm going to put this as 3 over the negative of the square root of 5. So the 3's are going to cancel. And so you get 2 over, let's just say, the negative of the square root of 5. And you can move this negative up here and just multiply by the square root of 5 over the square root of 5. So this becomes the negative of 2 times the square root of 5 over 5. Let me get rid of all this scratch work and just move this down. Okay, so we figured out all the stuff for theta. Now let's figure out the stuff for beta. So again, if you want the cosine, you can say cosine squared beta is equal to 1 minus your sine squared beta. So here the sine of beta is negative 1/3. So we need to square that. So that's going to give me 1/9. So let's put this as 1/9. And then this would be 9/9 like this. And so 9 minus 1 would be 8. So this is 8/9. Now, again, I'm in quadrant 4. That's why I put that this is positive. And so I would take the principal square root, and I would say this is the square root of 8 over the square root of 9, which is going to be, square root of 8 is the square root of 4, which is 2, times the square root of 2, over the square root of 9 is 3. And now we just need to figure out what is the tangent of beta. Again, that's your sine value, which is negative 1/3. And then multiplied by the reciprocal of the cosine value here, which is 2 times square root of 2 over 3. So I want 3 over 2 times square root of 2. So the 3's are going to cancel. Let's put the negative out in front. So negative, you have 1 over 2 times square root of 2. We need to rationalize the denominator. So times the square root of 2 over the square root of 2. And so at the end of the day, you're going to have the negative of the square root of 2 over 2 times square root of 2 times square root of 2 is the same thing as 2 times 2, which is 4. So what I want to do now is start off with the sine of theta plus beta. So you write out your formula. It's the sine of the first guy, so the sine of theta, times the cosine of the second guy, so cosine of beta, then plus you're going to have the cosine of the first guy, so theta, and then times your sine of the last guy, which is beta. Let me paste this stuff in here, and we could just plug in now. So when we think about the sine of theta, that's 2/3. So this is 2/3. The cosine of beta is going to be 2 times square root of 2 over 3. Then the cosine of theta is the negative of square root of 5 over 3. And then the sine of beta is going to be negative 1/3. So negative 1/3. Okay, so let's get rid of all of that and just go through and do our calculation. So 2 times 2 would be 4, then times the square root of 2 over 3 times 3 is 9. Then plus negative times negative is positive. This is just going to be the square root of 5 over 9. So really you could just write that with a common denominator and say 4 times square root of 2 plus square root, and let me make this a little bit better. So the square root of 5 over 9. Let me grab this real quick. And the answers are a bit hard to read, but I'm just going to put this up here and say this is the sine of theta plus beta. It equals this. So right now you see that you have 4 times square root of 2 plus square root of 5 over 9 right here. And you have the same thing here. Now, this one doesn't have that, and this one doesn't have that, and this one doesn't have that. So at this point, you can cross these out. But typically, I don't do that. I just circle the one that it is. So let's just not do that. Now, let's go back, and we're going to do the tangent of theta plus beta. And I'm not going to write out the formula. I think we should probably go a little bit faster. So the first thing is you want the tangent of theta. Okay, so that's negative 2 times square root of 5 over 5. And then the sine's going to match. So this is a plus. And then you're going to want your tangent of beta. So I guess because it's a negative, you could just put a minus here. And then you have the square root of 2 over 4. Then this is over. You have 1. And then the sign is different from this one. So minus, you're going to have this guy times this guy. Let me wrap this so I don't make a sign mistake. So negative 2 times square root of 5 over 5 times negative square root of 2 over 4. Okay, I'm going to grab this. So what I'm going to do first is just multiply this. So negative times negative is positive. Let me get rid of this. And then 2 times square root of 5 times square root of 2, that's 2 times square root of 10. So 2 times square root of 10. And then 5 times 4 is 20. Now, I did not cancel between numerator and denominator because what's going to happen is you have 5 and you have 4, and now you have 20. So you can just do this like this and multiply by 20 over 20 because that's your LCD. If you wanted to cancel, then you have to end up doing more work. But again, it's personal preference. So this is going to get distributed here and here. This is going to get distributed here and here. So this would give me 20 divided by 5 is 4. 4 times negative 2 is negative 8. And then times the square root of 5. And then minus 20 divided by 4 is 5. So you'd have 5 times square root of 2. This is over. 20 times 1 is just 20. And then minus the 20 divided by 20 would be 1. So this is 2 times the square root of 10. Okay. Let me actually grab this now, and let's paste this in here. So you have a radical in the denominator, so you're going to want to get rid of that. So let me multiply by 20 plus 2 times square root of 10 over 20 plus 2 times square root of 10. So I know this problem is a bit messy. So let's do FOIL in the numerator. So negative 8 times 20 is going to be negative 160, and then times the square root of 5. And then from there, you would have negative 8 times square root of 5 times 2 times square root of 10. So basically, in that case, negative 8 times 2 is negative 16. Square root of 5 times square root of 5 would be 5. And then times the square root of 2. Okay, so I broke the square root of 10 up into the square root of 5 times the square root of 2. So negative 16 times 5 would be negative 80. So this is negative 80 times the square root of 2. Okay, from here, you have negative 5 times square root of 2 times 20. So that's going to be minus 100 times the square root of 2. Let me slide this down here. And then lastly, you have negative times positive, which is negative, 5 times 2, which is going to be 10. Now here you have square root of 2, and again, square root of 10 is square root of 2 times square root of 5. So square root of 2 times square root of 2 is going to be 2, and then times the square root of 5. So this becomes negative 20 times the square root of 5. Now, before I do anything else, you can combine like radicals here. So this guy and this guy and this guy and this guy. So negative 80 minus 100 would be negative 180, and then times the square root of 2. So let me put that like that. And then negative 160 minus 20 would be negative 180, and this would be times the square root of 5. So let me get rid of that. Okay, so that's not so bad. So let's put this over. Down here, you're going to square the first guy. 20 squared is 400. and then minus square this guy. So 2 squared is 4. The square root of 10 squared is 10, so this is going to be 40. Okay, so let's say this is equal to, now 400 minus 40 is going to be 360. So let's just do that now. And if you think about it, 360 divided by 180 is going to be 2. So this is going to work out quite nicely for us. I'm going to pull out 180 here, and that's going to leave me with the negative of the square root of 5, and then minus the square root of 2, and this is going to be over 360. I'm going to cancel this with this, and this is going to be a 2. And so this is going to be equal to, I'm going to have the negative of the square root of 5 minus the square root of 2 over 2. Now what you could do is pull this negative out. So you could put the negative of the square root of 5 and then plus the square root of 2 over 2. So let me grab this and let me move this up a little bit higher so we can fit everything in. And I'm just going to slide this a little bit lower. So this is my tangent of theta plus beta. All right, for this guy and this guy, everything is exactly the same. All right, so we have a match in each case. You have the negative of the square root of 5 minus the square root of 2 over 2. And again, I just wrote it like this for clarity, just because we need to think about the sign. But you could write this as the negative of the square root of 5 plus the negative of the square root of 2, or minus the square root of 2 over 2. So this guy and this guy, they both match what we have here. The only difference is, in this case, it says theta plus beta is in quadrant 1, and in this case, it says theta plus beta is in quadrant 2. Well, again, you think about your all students take calculus. The sine value here is positive, and the tangent value here is negative. So you can't be in quadrant 1, so this one's out. You have to be in quadrant 2, right, where sine is positive and tangent is negative. So this is going to be the correct solution. All right, let's take a look at the quiz. For question 1, we're asked to find the exact value. We are given that the cosine of theta is equal to the negative of square root of 110 over 11. We're also told that theta is in quadrant 2, and we want to find the cosine of 2 theta. So let me grab this real quick, come down here and paste this in. So the identity you're going to want to use, if we come back to the handout here, let me scroll up. So double angle identities, use the one here where it says cosine of 2a is equal to 2 times cosine squared a minus 1. So if I wanted the cosine of 2 theta, it would be equal to 2 times my cosine squared theta, then minus 1. So let's just plug in for what we have. I'm going to erase this, and I'm going to put negative square root of 110, and then over 11. Let me slide this down here a little bit. This would be squared, so minus your 1 there. So if I square this right here, I'm going to get the square root of 110 squared is 110. 11 squared is 121. The negative is going to go away. Squaring a negative gives you a positive. So what I would do here is say this is 2 times 110 over 121, and then minus 1. So this, 2 times 110 would be 220. Let's just do that now. And what I'll do is get a common denominator. So I'll say this is 121 over 121. And so this would be 220 minus 121. That's going to be 99. And then over 121. Well, 99 is 9 times 11. 121 is 11 times 11. Let's cancel a common factor of 11. And we'll say the cosine of 2 theta is going to be 9 over 11. So let's come back up here. So for my cosine of 2 theta, I want 9 over 11. All right, let's take a look at question 2. So here we're given that the tangent of theta is equal to negative 1/2. And then we're also told that theta is in quadrant 2. And we want to find the cosine of 2 theta. So let me grab this and come down here. Now, there's a lot of ways you could find the answer here. If you go back to the handout, if you look through all the cosine of 2a's that you don't have anything with tangent. So you're going to need to figure out either the cosine of a or the sine of a. In this case, I think we're working with theta. So the cosine of theta or the sine of theta. So you can just pick which one you want to work with. I'm just going to use the same formula I used last time. So 2 times cosine squared a minus 1. So let me come back here and put this is equal to 2 times cosine squared theta minus 1. So how do I get the cosine of theta? Well, if we go back, again, to the little handout, go up to the Pythagorean Identities, and you have this tangent squared theta plus 1 equals secant squared theta. So let's use that. So we have that tangent squared theta plus 1 is equal to secant squared theta. So we'll find secant of theta, and then we can find the reciprocal to get the cosine of theta. We can plug in and use this. And again, there's other ways to do this, but I think this would probably be the best in this case. So for the tangent of theta, it's -1/2, and we want to square this. So this would end up giving me 1/4. And so then you want to add this to 1. So let's say this is 4/4. So this would be 5/4. Okay, so let me actually reverse the order here and say secant squared theta is equal to 5/4. Now we're told that theta is in quadrant 2. In quadrant 2, secant of theta and cosine of theta, they're both going to be negative. So what I'll do is say this is the secant of theta is equal to the negative square root of 5/4, which equals the negative of the square root of 5 over the square root of 4 is 2. So that's my secant of theta. Now, for the cosine of theta, you're going to want to find the reciprocal of this. So the cosine of theta is going to be equal to, I'm going to say this is -2 over the square root of 5. Now, normally I would tell you to rationalize the denominator, but in this case, notice that you're plugging it in and you're going to square it. So I would just leave it in this form. You don't really need to rationalize the denominator in this case because you're not presenting that as an answer. So negative, you have 2 over the square root of 5. Let's get rid of this, and let's just plug in here. So I'm going to plug in, let me actually slide this down just a little bit so it's out of the way. So this is the negative of 2 over the square root of 5, and of course this is squared. Okay, so now we are ready to go. So this would be 2 times, if I square a negative, that's going to go away, right? -1 squared is just 1. So then 2 squared would be 4, and the square root of 5 squared is 5. And then you have -1. Now, because the denominator there is going to be 5, let's write this as 5/5. And so 2 times 4 is 8. So this would be 8/5 minus 5/5, which would give me 3/5. So my cosine of 2 theta is 3/5. So coming back, I want to select the cosine of 2 theta is equal to 3/5. All right, let's take a look at question 3. So we want to complete the identity. And what we have here is cosine squared x, and then times sine of 2x, and then times the secant of x. So I want to grab this real quick and just simplify it and see if I can get it to match one of these guys. So a lot of these you can eliminate right away. So I would just write these choices down and just keep going through and manipulating and see if you can get a match. Let's come through here and paste this in here. And let's see what we can get here. So first, if I have cosine squared x and secant of x, well, what I can do is I can say that this is cosine of x times cosine of x times secant of x times sine of 2x. So that's the first thing I'm going to do. Let me put this over here. And actually, let me put equals like this. And what I'll do here is say that cosine of x times secant of x, that's 1. Right? Because this is the cosine of x times 1 over the cosine of x. 1 over the cosine of x is what the secant of x is by definition. So what you can actually do is cancel this away and put that as a 1. So now what I have is cosine of x times sine of 2x. Now let me go back to my choices and see what we have. You see that this one has cosecant of x in the denominator, and here you have sine of 2x. So what I would want to do is write the sine of 2x using this identity as 2 times the sine of x times the cosine of x. So let's say that this is the cosine of x times 2 times the sine of x times the cosine of x. And now what I can do is set this up by saying the sine of x is the same thing as 1 over the cosecant of x. So that'll give me my cosecant of x in the denominator that I want. So let me say that this is the cosine of x times the cosine, let me make this a little bit better, of x times 2 over the cosecant of x. So now we're getting somewhere. Let's go back up. And so I have my cosecant of x down here. So it looks like this is the one that I'm going to want to match. You have cosine of 2x plus 1 in the numerator there. So how can we get a match? Well, remember, you could write this as 2 times cosine squared x over cosecant of x. Now 2 times cosine squared x, if we come back, here you have 2 times cosine squared a. If I added 1 to each side, you could say that's equal to cosine of 2a plus 1. So I'm going to say that this is cosine of 2x plus 1 over your cosecant of x. So let me grab this and paste this in, and you see that's exactly what we have here, right? So cosine of 2x plus 1, that's the numerator. It's over the cosecant of x in the denominator. So this would complete the identity. So that guy right there. All right, for question 4, we're asked to find the exact value. So we have negative 5 times the sine of pi over 12, and then times the cosine of 5 pi over 12. Let's grab this real quick, and we'll come down here, paste this in. And so going back to the formula sheet, if you look at the product to sum identities, then what you have here is you're looking for sine of some angle A times cosine of some angle B. So that's what you have here. So it's 1/2 times the quantity sine of A plus B plus the sine of A minus B. So just remember that. So we'll come over here, just take the negative 5 and write it out in front of, you could do brackets or parentheses. So this is 1/2 times, inside the brackets, you have the sine of A plus B. So this guy plus this guy. So pi plus 5 pi is 6 pi over 12. That's going to end up being pi over 2. So this is pi over 2. And you could replace that now. Most people know the sine of pi over 2 is the sine of 90 degrees. It's 1. Let's just leave it. So then you're going to have plus. Now you have the sine of A minus B. So pi over 12 minus 5 pi over 12. So that's going to be negative 4 pi over 12. So that would be negative pi over 3. Now, if you have a negative there, remember sine is an odd function, so you can pull this out and you can write it like that. Okay, let me close this down, close this down. And so now I'll have negative 5/2, just multiplying there, times inside of the brackets. The sine of pi over 2 again is 1, and then minus the sine of pi over 3. Pi over 3 is 60 degrees. The sine of 60 degrees is square root of 3 over 2. Close that down. And so now I'm just going to distribute. So negative 5/2 times 1 is negative 5/2. Negative times negative is positive. And so what you'd have here is 5 times square root of 3 over, you'd have 2 times 2, which is 4. Okay, so getting a common denominator here, I'll just multiply this by 2 over 2. And this gives me negative 10 plus 5 times square root of 3 over the common denominator of 4. Let's grab this real quick, come back up here and answer. So I'm looking for this guy right here. So negative 10 plus 5 times square root of 3 over 4. All right, for question 5, we're asked to find the exact value. So we have negative 3 times the sine of 15 degrees, and then plus 3 times the sine of 285 degrees. All right, so what you notice here is you have the sine of some angle, then you have plus, and you have the sine of some angle. Now, you have this 3 and this negative 3 that's kind of in the way. If you just had a number outside here, it wouldn't matter, right? Because you could put the negative 3 out in front of some parentheses, but you have this 3 here that's going to stop you. So what you'd have to do is actually factor out a negative 3. Go ahead and pull that out. And then inside you would have the sine of 15 degrees. Now minus, because you pulled out a negative, you would have the sine of 285 degrees. Close that down. And now you can use your formula. So coming down here, here's the sum to product formulas. And so I'm looking for sine of some guy minus sine of another guy. So it looks like we want this second guy here. Sine of A minus sine of B is 2 times cosine of A plus B over 2 times sine of A minus B over 2. Okay, so this would be negative 3 times, you have 2 times, you have the cosine of A plus B over 2. So 15 degrees plus 285 degrees is 300 degrees, divided by 2 is 150 degrees, and then times your sine of A minus B over 2. So 15 degrees minus 285 degrees is going to be negative 270 degrees, and then if you divide that by 2, you would get negative 135 degrees. Okay, let's slide down here, and let's think about what we have. So in this particular case, negative 3 times 2 would be negative 6. And then times the cosine of 150 degrees, you're in quadrant 2. You have a 30-degree reference angle. So that's going to be the negative of the square root of 3 over 2. Remember, cosine is negative in quadrant 2. Then times, for the sine of negative 135 degrees, Again, that's the negative of the sine of 135 degrees. So sine is positive in quadrant 2, and you have a 45-degree reference angle. So the sine of 45 degrees is square root of 2 over 2. So this would end up being the negative of the square root of 2 over 2. Okay, so negative times negative times negative is negative. So let's come down here and put this as a negative. And then let me cancel this 6 with this 2, and that'll give me a 3. So let's go 3 times square root of 3 times square root of 2, which is 3 times square root of 6 over, just have this 2 left for the denominator. So that gives me the negative of 3 times square root of 6 over 2. So let me grab this, come up here, paste this in. So I'm looking for this answer right here. So the negative of 3 times square root of 6 over 2. All right, let's take a look at the quiz. For the first question, we're asked to find the exact value. We're given the cosine of 247.5 degrees. So we're going to end up using our half angle identities. And this guy right here where it says the cosine of a over 2 is equal to plus or minus the square root of 1 plus the cosine of a over 2. So you could do it like this. You could say this is the cosine of, you just double this guy. So 247.5 degrees, if you multiply it by 2, you're going to get 495 degrees. And then you're just going to divide by 2. So this is your a over your 2. So you just plug into the formula. So we'll go ahead and say that this is plus or minus. Now, in this particular case, again, you always think about this guy right here. I'm trying to find the cosine of 247.5 degrees. Forget about all this business right here, okay? So this angle right here that I'm trying to find the cosine of, it's going to be in quadrant 3. Cosine is negative in quadrant 3, so I want the negative of the square root of 1 plus the cosine of 495 degrees over 2. Now, in this case, you have 495 degrees here, so you need to find the coterminal angle. So 495 degrees minus 360 degrees, that's going to be 135 degrees. So I could say that this is the same as the cosine of 135 degrees. A 135 degree angle lies in quadrant 2, and the reference angle is going to be 45 degrees. So because it's in quadrant 2, it's going to be negative, and so it's going to be the negative of the square root of 2 over 2. So let's say that this is equal to the negative of the square root of 1, we'll go minus the square root of 2 over 2, and this is over 2. The easiest way to do this would be to multiply this by 2 over 2. So I'm just going to distribute this there, and then there. Okay, so let's say this equals, come down here, we'll say the negative of the square root of 2 times 1 is 2, and then minus the 2's would cancel, so you have the square root of 2, and then 2 times 2 is going to be 4. Okay, so I can simplify a little bit more here. Let's say this is equal to the negative of the square root of 2 minus the square root of 2 over the square root of 4 would be 2. So this would be my answer here. Let me grab it real quick, and I'll just paste this in, and I'll say this is equal to this. So the cosine of 247.5 degrees is going to be equal to the negative of the square root of 2 minus the square root of 2 over 2. So this right here is the answer you're looking for. So the negative of the square root of 2 minus the square root of 2 over 2. That's what you want. All right, let's look at question 2. So again, we want to find the exact value. So we're given the tangent of 11 pi over 8. Whenever you're asked to find the exact value with tangent, it's always a ton of work. This problem may have frustrated you because if you look at the answers here, I'm just going to tell you in advance, we're going to go through it anyway. The answer you should get is 1 plus the square root of 2. But if you don't use a specific formula here, you're going to get something that looks different, but it's going to be the same value if you punched it into the calculator and got the decimal approximation. So let me show you what I mean. Let's go down here. And let me start by just actually getting the angle measure in terms of degrees so we can think about it more cleanly. So 11 pi over 8 times, I'm just going to say this is 180 degrees over pi. Let's cancel this pi with this pi. 180 divided by 8 is 22.5. And then 22.5 times 11, that's going to be 247.5. So this is 247.5 degrees. Let me just write this is 247.5 degrees. And a lot of times this is just easier to figure out what quadrant you're going to be in. So this is going to be in quadrant 3. So you can erase it now. You don't really need it. You can work with degrees if you want, but typically if you get radians, your teacher wants you to do this in radians. So now what I'm going to do is say this is 11 pi over 8 times 2. So this would be 4 and this would cancel. So this is 11 pi over 4. And then I'm just going to divide by 2 so I can use my formula, right? I haven't done anything illegal. So this is equal to, so let's come down here. If you use this guy right here, you're not going to get an answer that matches. Again, you'd have to punch it into your calculator and approximate it and get a match that way. But if you use this one, let's just use this one and I'll show you this one. This one requires a sign. This one does not. So let's come back up here. Again, this is plus or minus. Now, again, this was 247.5 degrees. That's in quadrant 3. Tangent's positive. So let's say this is the square root of, it's 1 minus the cosine of this guy right here. So the 11 pi over 4. And then over 1 plus the cosine of this 11 pi over 4. Okay, let's put equals here. And let's slide down. Now, first off, 11 pi over 4 is greater than 2 pi. So what you could do is find the coterminal angle. So 11 pi over 4 minus, if you're subtracting away 2 pi and you want a common denominator, multiply by 4 over 4. This would be 8 pi. So 8 pi over 4. And this is 3 pi over 4. So most of you know this is 135 degrees. Again, if you don't, you just pull out your unit circle or do a quick conversion. So the cosine of 3 pi over 4, or the cosine of 135 degrees, is going to be negative square root of 2 over 2, right? So the reference angle there is pi over 4, or 45 degrees. And so the cosine of 45 degrees is square root of 2 over 2. 135 degrees is in quadrant 2, so we know this is negative. So this would be minus a negative square root of 2 over 2, which is plus the square root of 2 over 2. And this would be minus the square root of 2, and let me do that better. So the square root of 2 over 2. Okay. At this point, I would multiply by 2 over 2. So this is going to get distributed here and here and here. Okay. So let's say this is the square root of 2 times 1 is 2, and then plus your denominator here is going to cancel with this. So this is just the square root of 2. And down here, 2 times 1 is 2. And then minus the denominator is going to cancel, so just the square root of 2. Right? So whenever you see this pattern here, just multiply the numerator and denominator by the conjugate of the denominator. So you want to say this is 2 plus the square root of 2 over 2 plus the square root of 2. Okay, so this is the square root of, let me wrap this for clarity, like this in each case. So this is x plus y quantity squared. So square the first guy, 2 squared is 4. Then plus 2 times this guy times this guy, 2 times 2 is 4. Then times the square root of 2. Then plus the last guy, which is square root of 2 squared, which is going to be 2. 4 plus 2 would give me 6. And then this is over. Square this guy, 2 squared is 4. And then minus square this guy, the square root of 2 squared is 2. So this is 4 minus 2, or 2. Now, what you can do is say this equals the square root of, factor out a 2 in the numerator. So this would be 3 plus 2 times square root of 2 over 2. And then I'm just going to cancel this 2 with this 2. So this leads me to an answer of the square root of 3 plus 2 times the square root of 2. So let me grab this. And I'm going to come back up here. And so I'm just going to say this is equal to this. Now, I don't see this answer anywhere here. So what you'd have to do is punch this into your calculator, and you get about 2.41, let's just say 4. Now, if you punch this into your calculator, 1 plus square root of 2, you're going to get the same decimal approximation. So I'm just going to circle that, and we're going to say that's our answer. And let me just erase this. I'm going to show you how you can get this using the other formula. So let's come back down to this right here. And now I'm just going to use the second one. So the tangent of a over 2 is equal to the sine of a over 1 plus the cosine of a. So this is going to be equal to the sine of 11 pi over 4 over 1 plus the cosine of 11 pi over 4. Now remember, we found the coterminal angle for 11 pi over 4. It was 3 pi over 4. And again, that's going to be 135 degrees. So just think about the sine of 135 degrees. That's going to be the square root of 2 over 2. And then this is over 1 plus, again, the cosine of 135 degrees is the negative of the square root of 2 over 2. So let me just write minus the square root of 2 over 2. And so from here, I can just multiply by 2 over 2. So this goes here, and then this is going to go here, and then here. So we would have the square root of 2 only, right? Because this would cancel with this. And then over, you would have 2 times 1, which is 2. And then minus the denominator would cancel. So this is the square root of 2. So now I would multiply by 2 plus the square root of 2 over 2 plus the square root of 2. And this equals, you would have square root of 2 times 2, which is just 2 times square root of 2. and then plus square root of 2 times square root of 2 is 2. And this is over. Down here, you can just square the first guy. 2 squared is 4. And then minus square the last guy. Square root of 2 squared is 2. So 4 minus 2 is 2. And of course, what you could do is just factor out a 2 here. And this would be the square root of 2 plus 1 here over 2. So that cancels. And you get your square root of 2 plus 1. Again, coming back up here, square root of 2 plus 1, or 1 plus the square root of 2. All right, let's take a look at question 3. So for this one, we want to find the sine of x over 2. So let me write that out. So the sine of x over 2. This is given the fact that we have the tangent of x is equal to negative 12 over 5. And we're told that x is greater than 90 degrees and less than 180 degrees. So we're in quadrant 2 for x. Again, we got to figure out where we are for x over 2. So for my x over 2, again, you're just going to divide each part by 2. So this is 45 degrees. And then this over here would be 90 degrees. So x over 2 is greater than 45 degrees and less than 90 degrees. So x over 2 is going to be in quadrant 1. Now, let's think about this guy right here. You see your tangent value is negative because you're in quadrant 2. So the x values are negative and the y values are positive. So really, you could say that this right here is 12 over negative 5. So let me put x is negative 5 and y is going to be 12. I think at this point we know that the r value here is 13 because you're working with a 5, 12, 13 right triangle. Again, if you want to do it, you can say r equals the square root of negative 5 squared is 25. And then plus 12 squared would be 144. And so 25 plus 144 is 169. And if you take the square root of 169, you get 13. So if you want to find the cosine of x, this is going to be negative 5 over 13. Okay, so let's use this information and plug in to our little formula. The sine of a over 2 is equal to plus or minus the square root of 1 minus the cosine of a over 2. So coming back, we're going to say that the sine of x over 2 is equal to, we're in quadrant 1, so we just want the principal square root of 1 minus the cosine of x. In this case, that's negative 5 over 13. Minus a negative is plus a positive, so plus 5 over 13. And this is over 2. So let's multiply this by 13 over 13. So I'm just going to distribute that like that. And so this would be the square root of 13 plus 5 over 26. So 13 plus 5 is going to be 18. So what is 18 over 26? Well, each guy is divisible by 2. 18 divided by 2 is 9. And 26 divided by 2 is 13. So let's go ahead and say that this is the square root of 9, which is 3, over the square root of 13. So I'll multiply this by the square root of 13 over the square root of 13. And this is 3 times the square root of 13 over 13. So coming back up, I want this one, 3 times square root of 13 over 13 for the sine of x over 2. All right, let's take a look at question 4. So we want to find sine of x over 2. And we're given that the sine of x is equal to negative 3/5. And we're given that x is greater than 270 degrees and less than 360 degrees. So at this point, let's just say that x over 2 is greater than 270 degrees divided by 2 is 135 degrees. We'll say it's less than 360 degrees divided by 2 is going to be 180 degrees. So we know that x over 2 is going to be in quadrant 2, whereas x is going to be in quadrant 4. So sine of x is negative 3/5. So we need the cosine of x. And again, we know cosine is positive in quadrant 4, and this is just going to be 4/5. Again, how did I do that? It's a 3, 4, 5 right triangle. So if I'm in quadrant 4, then my y value here is negative 3. My r value here is 5. And again, you just use your r is equal to the square root of x squared plus y squared. So here you have negative 3. If you square that, you get 9. Then plus, let's say, x squared here. And you can square this and get rid of this. And then basically the r is 5. So let me plug that in. This would be 25 here. And just subtract 9 away from each side. And you're going to get x squared is equal to 16. Again, you want the principal square root here because you're in quadrant 4 and the x values are positive. So this is just going to be x is equal to 4. So let me put x equals 4 there. So that's how I get my cosine of x is equal to 4 over 5. Okay, let's get rid of this. We don't need this anymore. We're just going to plug into the formula. And let me show you this one more time, in case you forgot. So the sine of a over 2 is equal to plus or minus the square root of 1 minus the cosine of a over 2. So coming back, this is going to be that the sine of x over 2 is equal to, now again, x over 2 is in quadrant 2. So sine is positive. So I want the principal square root of 1 minus the cosine of x is 4 over 5. And this is over 2. Let me slide down here. I'll put equals over here. So this is the square root of. Let me multiply this by 5 over 5. And this is going to come in here and here. And this is going to go there. 5 times 1 is 5. Then minus. 4/5 times 5 is just 4. And this is over. 2 times 5 is 10. So this equals, we're going to have the square root of 5 minus 4 is 1 over. You're going to have just 10 down here. So this is the square root of 1, which is 1, over the square root of 10. Let's go ahead and rationalize the denominator and say this is times the square root of 10 over the square root of 10. So we're going to get the square root of 10 over 10. So coming back up, I want this guy right here. So the square root of 10 over 10. All right, let's take a look at question 5. So we want to complete the identity. And what we have is 2 over 1 plus the cosine of x minus tangent squared x over 2. So we're trying to match something here. So let's grab it real quick. And the first thing I would do, since I'm in this section, you think about this 2 over 1 plus cosine of x. That looks pretty familiar. If you go back, you see that that's the reciprocal of this radicand here. So this is 1 plus cosine of a over 2. And that's just 2 over 1 plus, in this case, cosine of x. So what you could do here is really say, let me get rid of this, and I'll write this out fully so nobody's lost. If I had, let's say, the cosine of x over 2, this would be plus or minus the square root of, you have 1 plus the cosine of x over 2. Okay, now what if I squared both sides of this? So I square this and I square this. So I could say cosine squared x over 2 is equal to, I would just have the radicand. So 1 plus cosine of x over 2. Okay, so now what if I wanted secant squared of x over 2? Well, it's just the reciprocal of this. So the secant squared of x over 2 is equal to 2 over 1 plus cosine of x. Okay, so now I have a match. What I can do here is say that this right here is equal to secant squared of x over 2. So let me get rid of this. And I'll just say that this is equal to secant squared of x over 2, and then minus tangent squared of x over 2. Now, if you go back to your Pythagorean identities that we learned a long time ago, let's come all the way back up here. You see the second one, it says tangent squared theta plus 1 equals secant squared theta. So let me write that out. Tangent squared theta plus 1 equals secant squared theta. Well, what I could do here is subtract tangent squared theta away from each side, and that would give me that secant squared theta minus tangent squared theta equals 1. So here we have secant squared x over 2 minus tangent squared x over 2. So this is equal to 1. So I can just say this is equal to 1, and I can go back up and just say this is what I want. So we'll say it's equal to 1. That would complete the identity. All right, let's take a look at the section quiz. For the first question, we're asked to use the fundamental identities to determine which is true. We are given that the cotangent of theta is equal to the negative of the square root of 2 over 4. We're also told that the cosine of theta is greater than 0, or you could say that it's positive. Cotangent is negative, so that's going to occur in quadrants 2 and 4. Cosine is positive, that occurs in quadrants 1 and 4. So the overlap is going to be in quadrant 4. So let's say that theta is in quadrant 4. So now what I would do is I would go through and I would calculate everything. Again, just use your identities. First and foremost, we know that the tangent of theta is just the reciprocal of this. So the negative of 4 over the square root of 2. You always want to rationalize your denominator. So we're going to multiply by the square root of 2 over the square root of 2. So this is the negative of 4 times the square root of 2 over square root of 2 times square root of 2 is 2. Now you can cancel a common factor of 2 between here and here. So this would be the negative of 2 times square root of 2. Let me erase this from here. And the tangent of theta is the negative of 2 times square root of 2. Now, let's think about how to get the other guys here. So coming to our little handout, going to the Pythagorean Identities, remember you have tangent squared theta plus 1 equals secant squared theta. You could also go 1 plus cotangent squared theta equals cosecant squared theta, whichever one you want to use, it doesn't really matter. Let's just say that tangent squared theta plus 1 equals secant squared theta. So I can use this to get secant and also cosine, and then I can pretty easily find sine and cosecant once I have cosine. So let's come down here and just plug in. So remember, this guy is going to be squared. So you're going to plug in -2 times square root of 2, and you're going to square that. Then plus 1 equals secant squared theta. Let's get rid of this. We don't need this anymore. And I'm just going to go above. So if I square this, I get 4 times 2, which is going to be 8. And then this is plus your 1, and this equals secant squared theta. So 8 plus 1 is going to be 9. Now we're in quadrant 4, and again, cosine and secant would be positive in quadrant 4. So you want to take the principal square root here and say that the secant of theta is equal to the principal square root of 9, which is 3. So now I know my secant of theta. Let me write this over here. The secant of theta is 3. And so that means the cosine of theta is going to be 1/3, right? It's just the reciprocal. Now I can find my sine of theta pretty easily. Remember, you have sine squared theta plus cosine squared theta equals 1. But you could write that as sine squared theta is equal to 1 minus cosine squared theta, and just solve for sine of theta. So let's come down here. And I'm just going to plug in for the cosine of theta. Remember, we have to square this. So 1/3 squared is 1/9. So let's write this as 9/9. 9 minus 1 is 8. So this is 8/9. Now we are in quadrant 4. And so I want the negative square root here. So I would say that the sine of theta is equal to the negative of, let's just say, the square root of 8 over the square root of 9. So this is the negative of, the square root of 8 is the square root of 4 times the square root of 2. Square root of 4 is 2, so this is the negative of 2 times square root of 2 over square root of 9 is 3. So that's my sine of theta. So this right here is the negative of 2 times square root of 2 over 3. Okay, let's get rid of this. And the last one to figure out is the cosecant of theta. So this is the negative of, we're going to take the reciprocal of this. So 3 over 2 times square root of 2. So multiply by the square root of 2 over the square root of 2. And so this becomes -3 times square root of 2 over, you basically have 2 times 2, which is 4. Okay, let's move this out of the way. And let me actually just erase this so this actually fits. I'm going to grab this and move this up here and just grab everything now. Okay, let's paste this in here. I know it's going to be hard to read. But basically, the first one is where we're going to get the match. The sine of theta equals the negative of 2 times square root of 2 over 3. So you have a match there. So I'm just going to erase all this. You'll find that the other ones are not going to work. And I'll just circle this one as the one that's true. All right, let's take a look at question 2 now. So again, we want to use the fundamental identities to determine which is true. So we are told that the cosine of theta is equal to -10 over 11. Maybe I can make that a little bit better there. And then we're also told that the sine of theta is greater than 0. So I really don't need to write this out. Cosine is negative and sine is positive. So where does that happen? Again, cosine would be negative in quadrants 2 and 3, and sine would be positive in quadrants 1 and 2. So that means I have to be in quadrant 2. So that's the overlap. So let me grab this real quick. And I think to save some space, I'm not going to write that theta is in quadrant 2. We'll just remember it. So first off, I'll just grab the secant of theta. So the secant of theta, and this is the reciprocal of the cosine of theta, so this is -11 over 10. Now to find the sine of theta, you have many options, but I'm just going to use sine squared theta plus cosine squared theta equals 1. And you can write that as sine squared theta is equal to 1 minus cosine squared theta, just a different form. And just plug in for the cosine of theta. So we're going to plug in a -10 over 11, and then of course, this is going to be squared. So what we'll do here is square this first. So the negative goes away. -1 squared would just be 1. 10 squared is 100, and 11 squared is 121. So this right here would be 100 over 121. You need a common denominator. So let's go 121 over 121. And then minus 100 over 121. So that's going to lead to 21 over 121. So let me write that like this. Okay, so now we're in quadrant 2. That means sine is going to be positive. So I can say that sine of theta is equal to the principal square root of this guy. And I'll just break that up as the principal square root of 21 over the principal square root of 121. And so this is what? 21 is 7 times 3, so you really can't simplify that any further. We would say this is just the square root of 21 over the square root of 121 is 11. Okay, let me clean this up, and I'll just write this answer up here more neatly. So we'll say that this sine of theta is equal to, this is the square root of 21 over 11. Maybe I'll move this down just a little bit. So again, this is my sine of theta. Now, to find the cosecant of theta, you just take the reciprocal of this guy, but keep in mind you have to rationalize the denominator. So this is the cosecant of theta is equal to, you would have 11 over the square root of 21. We'd multiply by the square root of 21 over the square root of 21. So this is going to be 11 times the square root of 21 over 21. Okay, so that's done. For the tangent of theta and the cotangent of theta, again, you can use identities if you want. You could go tangent squared theta plus 1 equals secant squared theta. You also have 1 plus cotangent squared theta equals cosecant squared theta. So you could use either one of those if you want. But I think it's probably better just to use the definition of tangent and just say that the tangent of theta is equal to the sine of theta divided by the cosine of theta. So the sine of theta is the square root of 21 over 11. And then I'm going to multiply by the reciprocal of this. So negative 11 over 10 like this. So these 11s are going to cancel. And you'll end up with the negative of the square root of 21 over 10. So let me write that out. So again, the negative of the square root of 21 over 10. All right, for my cotangent of theta, I just take the reciprocal of this. So the negative of 10 over the square root of 21. And I'll just multiply by the square root of 21 over the square root of 21. So this becomes negative 10 times square root of 21 over 21. So negative, you have 10 times square root of 21. And make that a little bit longer there. And this is over 21. Okay, now that we have everything, let me grab this real quick. And we'll just paste this in. I know it's a bit hard to read. But if you look at the choices here, we start with the sine of theta. And it says that it should be the square root of 21 over 4. Well, here it's the square root of 21 over 11. So this one's out. This is not going to be a match. So go to the tangent of theta. Now that says that it's negative 5/3. Well, the tangent of theta is the negative of the square root of 21 over 10. So this is not a match. So let's keep going down. Now we have the cosecant of theta is 11 times square root of 21 over 21. Cosecant of theta is 11 times square root of 21 over 21. So we have a match. We found the one that is true. All right, let's take a look at question 3. So this tells us to begin by writing each in terms of sine and cosine. Once this is done, simplify so that no quotients appear in the final expression and all functions are of theta only. So it says, note, your final expression may not contain sine or cosine. So let's write this out. We have sine of theta minus cosine of theta. And let me move this over here so it fits. This is times, we're going to have the cosecant of theta plus your secant of theta. Okay, let's write this in here. Again, I'm just going to replace this cosecant of theta with 1 over sine of theta and secant of theta with 1 over cosine of theta. So you're going to have sine of theta minus cosine of theta, and then times, this will be 1 over the sine of theta, and then plus 1 over the cosine of theta. Now, what I'll do from here is just use FOIL. So we'll go through and say my first terms, sine of theta times 1 over sine of theta is 1. So then we'll go plus sine of theta times 1 over cosine of theta would be sine of theta over cosine of theta, which is the tangent of theta. And then basically minus cosine of theta times 1 over sine of theta. So that would be cotangent of theta. And then lastly, you have minus cosine of theta times 1 over cosine of theta, which is 1. So you can see that 1 minus 1 would go away. That's going to cancel. And so you're left with the tangent of theta minus the cotangent of theta. So let's come back up. And this is what we want. So the tangent of theta minus the cotangent of theta. All right, for question 4, we're asked to choose the trigonometric expression that completes the identity. So we have the tangent of x plus the cotangent of x over the secant of x. We want to see if we can get a match anywhere. So let's grab this real quick. And let's come down here and paste this in. So the first thing I would try here is just write things in terms of sine and cosine. Generally speaking, that will work for a lot of your cases. In some cases, it doesn't. With this type of situation, verifying a trigonometric identity, there's really no set procedure. You just try stuff and see what works. So I'm going to go ahead and say this is sine of x over cosine of x, then plus cosine of x over sine of x. And this is over, for the secant of x, this is going to be 1 over the cosine of x. Okay, so let me actually drag this down here so we have a little bit more room to work. And traditionally, you'll put your equal sign like this. So let me just do that. And what I'm going to do now is multiply by sine of x times cosine of x over sine of x times cosine of x, just to clear the denominators. So this is going to go here, and this is going to go here. So let's slide down here and put equals. So sine of x times sine of x is sine squared x. Then cosine of x and cosine of x will cancel. Then plus. Here the sine of x's would cancel, so you have cosine squared x. And then this is over. Down here, the cosine of x and the cosine of x will cancel, so you have your sine of x. Now, if you think about your identities, sine squared x plus cosine squared x is 1, and this is over the sine of x. Now, 1 over the sine of x is the cosecant of x. So let's go back up and see if we have that. So we have 1 over sine of x. So that's what I'm looking for. It could have also been the cosecant of x. That's what I was thinking. So let's say this is 1 over the sine of x. So that would complete the identity. So this guy right there. All right, for question 5, we're asked to choose the trigonometric expression that completes the identity. Let's see, we have cosecant squared x over cotangent squared x. So let's grab this real quick and see what we can do. So I'm going to paste this in right here. Again, there's no set way to start. You can just start trying to just replace things. Usually what I do is just replace with sine and cosine. So let's say that, I'll just put this over here. So the cosecant squared x, you could say that that is 1 over sine squared x. This would be over for cotangent squared x. Let's say that's cosine squared x over sine squared x. Okay, so we know if we're dividing fractions, we're going to keep the first fraction unchanged. So this top guy. So 1 over sine squared x times the reciprocal of this guy. So you have sine squared x over cosine squared x. Let me grab this real quick and move it down so it's not in the way. And let me slide down here just a little bit. And so what we're going to have is this cancels with this. So you have 1 over cosine squared x. So that's going to be secant squared x. Let me come back up and look at the choices here. So I don't see 1 over cosine squared x, and I don't see secant squared x. But what I do see is tangent squared x plus 1. So I want you to remember that secant squared theta is tangent squared theta plus 1. So I can come back and say that secant squared x is 1 plus tangent squared x, or you could write that as tangent squared x plus 1 to match the form up there. So coming back, you want this one. So tangent squared x plus 1, you could write that in here. So tangent squared x plus 1. All right, let's take a look at question 6. We want to choose the trigonometric expression that completes the identity. So we have the cosecant of x times the cosine of x over, we have the tangent of x plus the cotangent of x. Okay, so looking through these guys, let me grab this real quick and see if we can get a match. So let me paste this in here. So what I see immediately is that I have cotangent of x here, and I actually have cotangent of x up here. So let me start by just writing this in a more clear way. So cosecant of x is 1 over the sine of x, and then times the cosine of x. So this right here, again, cosine of x over the sine of x, that's the cotangent of x. So let's put this over. You have the tangent of x plus the cotangent of x. So I'm going to write this, let me put equals over here, as the cotangent of x over the tangent of x plus the cotangent of x. So the reason I didn't write everything in terms of sine and cosine is because I immediately see that I have cotangent of x and cotangent of x. Well, what I could do is multiply the numerator and denominator by the tangent of x. So this is a common strategy here because tangent of x times cotangent of x would give you 1, right? So you're going to end up with 1, and then you're going to end up with 1, and this would be tangent squared x. So we know we can replace tangent squared x plus 1 with secant squared x, and I'm going to have 1 over secant squared x, which is cosine squared x. Okay, so hopefully you see where I'm going with this. So let's put equals here, and let me show this as coming in here, and this is going to there and there. Tangent of x times cotangent of x is 1, and this is over. Tangent of x times tangent of x is tangent squared x, and then plus tangent of x times cotangent of x is 1. Again, as I said earlier, the tangent squared x plus 1, we know that's secant squared x. So let's say that this is 1 over your secant squared x. And so to finish this up, 1 over secant squared x would be cosine squared x. Let's go back up and select this guy right here, this cosine squared x. And I'll just put this in here, the cosine squared x. That would complete the identity. Okay, let's take a look at question 7. So we're asked to determine if true or false. And we have the cosine of 42 degrees is equal to the cosine of, inside the parentheses, you have 30 degrees plus 12 degrees. So this is a very simple problem. There's nothing stopping me from adding 30 degrees and 12 degrees together and getting 42 degrees. So this would be that the cosine of 42 degrees is equal to the cosine of 42 degrees, which of course is true. Right? So this is true. All right, let's take a look at question 8. So here we want to determine if true or false. And we're given that the cosine of 74 degrees is equal to the cosine of 60 degrees times the cosine of 14 degrees plus the sine of 60 degrees times the sine of 14 degrees. So if you notice that this angle and this angle are the same, and then this angle and this angle are the same, and then you have a plus sign, you're thinking about the difference identity for cosine. So the cosine of A minus B is going to be the cosine of the first guy A times the cosine of the second guy B. And then this is a minus, so this becomes a plus. You have your sine of the first guy A times your sine of the second guy B. All right, so let me write this right side out. So this is cosine of 60 degrees times cosine of 14 degrees plus the sine of 60 degrees times the sine of 14 degrees. And again, just following this pattern here, this would be the cosine of the first angle, which is 60 degrees, minus the second angle, which is 14 degrees. And so really we could say this is the cosine of 46 degrees, right? Just do the subtraction. So let me say this is the cosine of 46 degrees. And so the cosine of 46 degrees is not the cosine of 74 degrees. Those guys are not going to be equal. So this is going to be false. Okay, let's take a look at question number 9. So we want to find one value of x that satisfies the following. So I have a little note here. We're saying that there are an infinite number of possible solutions. And when we get into the next section, we talk about solving trigonometric equations. I will show you exactly how to find all the possible solutions for an equation like this. For right now, we're just going to find one. So I'm going to write that we have the cosecant of 3 pi over 4 is equal to the secant of x. So let's grab this real quick and come down here. So like we talked about in the lesson, we can use something called the cofunction identities to solve this type of problem. The idea is that you have cosecant here. So if I could get cosecant over here, then I could just set the two angle measures equal, and then I could solve. So the way you're going to do that is you're going to say, well, the secant of x is equal to, normally you would say the cosecant of 90 degrees minus x like this, but we're working with radians. So for 90 degrees, let's plug in a pi over 2. So hopefully you can see that, well, this is secant of x and this is secant of x. And since secant of x is equal to the cosecant of, again, this pi over 2 minus x, well, what I'm going to do is just plug this in basically right here. And so that would give me cosecant of 3 pi over 4 is equal to the cosecant of this pi over 2 minus x like this. So now I have cosecant over here and cosecant over here. So now I can take this angle measure and set it equal to this angle measure and solve the resulting equation. So let's write 3 pi over 4 is equal to pi over 2 minus x. All right, what I'm going to do is add x to both sides. So let me go x plus this guy over here. And I'm going to show this as canceling. And let's just subtract 3 pi over 4 away from each side. And I'll show this as canceling. So let's say that we have x is equal to, we're going to have pi over 2, and then minus this 3 pi over 4. And to get a common denominator, let's multiply this by 2 over 2. So this would be 2 pi over 4. Let's just erase this and do this now. So this is 2 pi over 4, and then minus 3 pi over 4. So 2 pi minus 3 pi would be negative pi, and that's over the common denominator of 4. So x here is negative pi over 4. And again, this is only one possible solution of an infinite number. So let's come back up and just select that x is equal to negative pi over 4. Okay, let's take a look at question 10. Again, we are asked to find one value of x that satisfies the following. We have a little note here again that there are an infinite number of possible solutions. Just like I discussed in the last problem, when we get to the next section on solving trigonometric equations, we will talk about how to find all the possible solutions. So let me write out the problem here. We have that the cotangent of, you have this x minus 10 degrees is equal to the tangent of, we have the 2x minus 20 degrees. Okay, let me grab this real quick and let's paste this in here. All right. The idea here is you want to use your cofunction identities to have cotangent here and cotangent here, or if you wanted to, you could put tangent here and tangent here. The idea is that once you've done that, you can set the angle measures equal and you can solve the resulting equation. The hard thing here is that you don't have something simple like just the tangent of x. So what you have to do is actually think about your identity a little bit more deeply. Okay, so let's just say that we have the tangent of x is equal to the cotangent of this 90 degrees minus x. So this is the cofunction identity that we're going to work with. Now, instead of having x, now the angle is 2x minus 20 degrees. So let's translate that. So we have tangent of this 2x minus 20 degrees is equal to the cotangent of, again, I'm going to have my 90 degrees, and in the place of x, I'm going to have this guy right here, right? So that's the angle that I'm working with. So let me put a minus there, and I'm going to change colors again and wrap this in some parentheses. Maybe I'll slide this down so it fits. So this is going to be 2x minus 20 degrees. We'll close that down and then close this down. Okay, so this is what you're going to end up doing in the place of the tangent of 2x minus 20 degrees, since it's equal to this cotangent of the quantity 90 degrees minus this other quantity 2x minus 20 degrees, you're going to take this guy right here and you're going to plug it in for this guy right here, this whole thing right here. Okay, so then we're going to have that the cotangent of this x minus 10 degrees is equal to, again, just plug this in for this. So that gives me the cotangent of this 90 degrees minus 2x and then plus 20 degrees. I'm just distributing this in, and then let's close this down. And at this point, you could say that 90 degrees plus 20 degrees is 110 degrees. So I'll say this is the cotangent of x minus 10 degrees is equal to the cotangent of 110 degrees minus 2x. All right, so now that we have cotangent here and cotangent here, again, take this angle measure and set it equal to this angle measure and just solve the resulting equation. Okay, so let's set that up and say that we have x minus 10 degrees is equal to 110 degrees minus 2x. What I'm going to do is add 2x to both sides of the equation, and I'm going to add 10 degrees to each side of the equation. So let's cancel this and let's cancel this. So come down here, x plus 2x is going to be 3x. And this equals 110 degrees plus 10 degrees would be 120 degrees. So let's divide both sides of the equation by 3. And so let's cancel this with this and say x is equal to 120 degrees divided by 3 would be 40 degrees. So x equals 40 degrees would be one solution, again, of an infinite number. So let's come back up here and select x is equal to 40 degrees. All right, let's take a look at question 11 now. We're asked to complete the identity. We're going to have the secant of, we have pi minus x. So let's just grab this real quick and come down here and paste this in. So the first thing I'm going to do is write this in terms of cosine. So I'm going to say this is 1 over the cosine of pi minus x like this. And then from here, you can use your difference identity for cosine in the denominator. So let's say this is equal to 1 over, we'll go cosine of pi times the cosine of x. And then because this is a minus, I want a plus here. So we're going to go the sine of pi. and then times the sine of x. Okay, so looking at this, the cosine of pi, hopefully you know this from the unit circle, this is -1. So let me put that this right here is -1, and then the sine of pi is going to be 0. Okay, so what I'm going to do is say this is equal to, we'll go 1 over, you have the negative of cosine of x, and then because this is a 0, 0 times anything is 0, so this is what we have here. So let's come down here and just say this is equal to the negative of 1 over the cosine of x. Now 1 over cosine of x is the secant of x, so I'm just going to say this is equal to the negative of the secant of x, and then we can go back up, and we say we want this one, so the negative of the secant of x. So let me write that in here. So the negative of the secant of x, and that would complete the identity. All right, for question 12, we have the sine of s is 2/3. The sine of t is -1/3. We're told that s is in quadrant 2 and t is in quadrant 4, and we want to find the cosine of s plus t. Okay, let me start this problem off by coming down here and just say that we want the cosine of s plus t. And I hate when I use a plus sign next to a t. It gets super confusing. So let me wrap this so we know that's a plus sign. Okay, so this is going to be what? This is the cosine of s times the cosine of t. And then because this is a plus, you're going to get a minus here. You have the sine of s times the sine of t. So we need to find out what is the cosine of s and what is the cosine of t. We already know the sine of s and the sine of t. Let me go back up. And the sine of s is 2/3. So the sine of s is 2/3. And then the sine of t is -1/3. Let me grab these real quick and come back here and paste this in here. So I'm just going to arrow to this and say this is 2/3. And I'm going to arrow to this and say this is -1/3. Okay, so we need to figure out the cosine of s and the cosine of t. So let's just grab this real quick, and I'll come back up here. We'll just do it up here. I think there's enough room. So first and foremost, if the sine of s is 2/3, well, then you can find the cosine of s by saying cosine squared s is equal to 1 minus sine squared s. So for the sine of s is 2/3, and you're just going to square that. So that would be 2 squared is 4, and 3 squared is 9. So let's write this as 9 over 9. 9 minus 4 is 5, so this is 5/9. Now, I want you to look at the fact that s is in quadrant 2, and cosine will be negative in quadrant 2. So you want to say that the cosine of s is the negative of, let's say, the square root of 5 over the square root of 9 would be 3. So the cosine of s is negative square root of 5 over 3. So this right here is the negative of the square root of 5 over 3. And maybe I can make that a little bit cleaner here. So let me get rid of this and make this a little bit cleaner. And let's come back up. So now we need the cosine of t. Let me get rid of this and this. So we're told that t is in quadrant 4. So let's do the same thing. We're going to say that cosine squared t is equal to 1 minus sine squared t. And for the sine of t, it's -1/3. And then we're going to square that. So if I square the negative, it goes away. 1 squared is 1, and 3 squared is 9. So this -1/3, if I squared that, I would have 1/9. So let's write this as 9 over 9, and 9 minus 1 is 8, so this is 8/9. And then from here, again, I want the principal square root because I'm in quadrant 4. So the cosine of t is equal to, you'd have the square root of 8 over the square root of 9. So the square root of 8 is the square root of 4, which is 2, times the square root of 2, over, now you have the square root of 9, which is 3. So 2 times square root of 2 over 3. Let me get rid of this, and let me just paste this in. So this would be 2 times square root of 2 over 3. So let me put the multiplication symbol in there. So I know these problems are quite a bit of work, but you just set them up and then basically just go through and do the calculations. So I'll just say this is equal to, let me erase these arrows here like this. Let me put a minus sign and put a multiplication symbol there. Okay, so negative times positive is negative, and you have square root of 5 times square root of 2, which would be square root of 10, and then times 2. So this is 2 times square root of 10 in the numerator, and this is over 3 times 3, which would be 9. Then we have a negative times a negative, basically. So this would be plus. You have, let me write this as 2 over 3 like this, so this is easier to read. So 2 times 1 would be 2 over 3 times 3, which is 9. Okay, so coming down here, we'll go ahead and say that I can't really do a whole lot other than just to write this with a common denominator. So I'll say it's 2 minus 2 times square root of 10 over 9. You could factor out a 2, but what are you going to do with it? So I'm just going to write it like this. We'll go ahead and copy this, and we'll paste this in here. And let's see if we can get a match. So it looks like it's going to be this one. It's written in a different order. So here you have negative 2 times square root of 10. So negative 2 times square root of 10. And then plus 2. So it's just me rearranging the numerator. And then over 9. So this is what we want right here. All right, for question 13, we're asked to find the exact value. And we have the tangent of negative 5 pi over 12. Let me grab this real quick. All right, so the first thing is you could find the coterminal angle, or you could use the negative angle identity. So maybe it's easier just to say this is the negative of the tangent of 5 pi over 12 like this. Or again, find the coterminal angle. It's really up to you. Then I'm going to convert this to degrees. It's just easier to break things up. So I'm going to say this is 5 pi over 12 times. I'm going to say this is 180 degrees over your pi. So this guy right here, this would cancel. 180 divided by 12 is 15, and 15 times 5 is 75. So this is 75 degrees. Okay, so thinking about 75 degrees, you could break that up into 30 degrees plus 45 degrees. So in terms of radians, 30 degrees is pi over 6, and 45 degrees is pi over 4. So let's go ahead and say that this is equal to the negative of the tangent of, we'll go ahead and say pi over 4, again that's 45 degrees, plus pi over 6, again that's 30 degrees. So this is going to give me that 5 pi over 12 if I add it together. And you can pause the video and go through and get a common denominator. You'll see that you get that exactly. So let's now use our sum identity for tangent. So we'll say this is the negative of, you'll have your tangent of the first guy, so the tangent of pi over 4, and then plus the tangent of the second guy, so pi over 6. This would be over. You have 1. Again, this is a plus, this is a minus. You have the product of these two guys here. So the tangent of pi over 4 times the tangent of pi over 6. Let me just write this negative out in front like this, and let's put equals. So hopefully a lot of you know at this point that the tangent of pi over 4 is going to be 1, right? Because the cosine of pi over 4 is equal to square root of 2 over 2. And the sine of pi over 4 is equal to square root of 2 over 2. And so the tangent of pi over 4 will end up being the sine of pi over 4 divided by the cosine of pi over 4. So it's just square root of 2 over 2 divided by square root of 2 over 2. Same non-zero number divided by itself is 1. So we can go ahead and say that this guy right here would be 1 and this guy right here would be 1. So the negative of, we'll put 1 plus, I'll leave this blank for right now. This is over 1 minus, and this is a 1 being multiplied by something, so let's just leave it blank for right now. Now, how do we get the tangent of pi over 6? So let's just go ahead and say that the sine of pi over 6, again, this is 30 degrees. This is a half, and then the cosine of pi over 6, again, 30 degrees, this is square root of 3 over 2. So basically, you would take for the tangent of pi over 6 and say that, okay, well, it's the sine of pi over 6, which is a half, times the reciprocal of the cosine of pi over 6, which is 2 over the square root of 3. So this would cancel, and you're going to get 1 over the square root of 3. If I multiply by the square root of 3 over the square root of 3, I'm going to get the square root of 3 over 3. So this is the square root of 3 over 3. Okay, let's get rid of all of this. And so for this guy right here, I'll say this is the square root of 3 over 3. And then down here, I'll just say this is the square root of 3 over 3. Let's come to a new sheet here and think about what we can do. I could multiply the numerator and denominator by 3. So again, you got to think about this. This is going to come in here, and then here, and this is going to go here, and then here. So this is equal to the negative of, you have 3 times 1, which is 3, and then plus the 3's would cancel, so you just have the square root of 3, over, now you have 3 times 1, which is 3, and then minus the 3's would cancel, so the square root of 3. All right, so again, if you see something like this, the 3 minus the square root of 3 in the denominator, you can multiply the numerator and denominator by the conjugate of the denominator. So I'm going to multiply by 3 plus the square root of 3 over 3 plus the square root of 3. Let me actually wrap this for clarity so nobody gets confused. And we'll put equals, and I'll put the negative out here. So in the numerator, just use your x plus y quantity squared formula. So 3 squared is 9. And then plus, let me move this negative a little bit lower here so this is formatted a little bit better. You have 2 times this guy times this guy. So 2 times 3 is 6, and then times the square root of 3, and then plus the last guy squared. So the square root of 3 squared is 3. So 9 plus 3 would give me 12. So let's put that in now. And then this is over. Down here, again, square the first guy, 3 squared is 9. And then minus square the last guy, square root of 3 squared is 3. So 9 minus 3 is 6. Now, we can simplify further because what you can do here is pull out a common factor of 6 in the numerator. So this would be 2 plus the square root of 3 over this 6 down here. Let me again move this down a little bit for formatting. And let's come down here. And I'm just going to finish this up by canceling this 6 with this 6. And so I finally have my negative of the quantity 2 plus the square root of 3, which you could distribute the negative and say this is negative 2 minus the square root of 3. So this is what I'm looking for. Let's paste this in here. So I want this one right here. So negative 2 minus the square root of 3. All right, let's take a look at question 14. So we want to determine if true or false. So we have the sine of s plus t. Let me circle this plus here so we don't get it mixed up with the t. And this is over. We have the cosine of s times the cosine of t. And we're saying this is equal to the tangent of s plus the tangent of t. Let me circle this plus here again so nobody gets confused. Let's grab this real quick and we'll go to another page here. And let's just think about whether or not this is true or not. This side on the right, I'm just going to leave that alone. On the left, I'm going to expand this numerator here using my sum identity for sine. So that would give me that this is the sine of the first guy, so s, and then times the cosine of the second guy, so t, and then the sign matches. So this is a plus here. Again, let me circle this so nobody is lost. Then we have the cosine of the first guy, so that's s, and then times the sine of the second guy, so that's going to be t. Now this is over this denominator here, which is the cosine of s times the cosine of t. Let me move this down here a little bit and say this is equal to the tangent of s plus the tangent of t. And let me just circle that real quick. Okay, you could split this up into the sine of s times the cosine of t over the cosine of s times the cosine of t. And then you could say this is plus, you have the cosine of s times the sine of t over the cosine of s times the cosine of t. So you have a common denominator here, so you can go from this form to this form or from this form to this form. If you look at this, cosine of t over cosine of t would cancel. And then here, cosine of s over cosine of s would cancel. So again, we're saying this is the tangent of s plus the tangent of t. So when I think about this, sine of s over cosine of s, well, that is the tangent of s. And then plus the sine of t over the cosine of t, that's going to be the tangent of t. So this is equal to the tangent of s plus the tangent of t. Right? So these two sides are exactly equal. Let's come back up here and say that this is true. All right, let's take a look at question 15. So we have the sine of u is negative 7 over 25, and the cosine of v is negative 4 over 5. U and v are both in quadrant 3, and we want to find the tangent of u minus v. So let's come down here and write that the tangent of u minus v is equal to, this is the tangent of u minus the tangent of v over 1 plus, you have the tangent of u, so the tangent of u times the tangent of v. So something like this takes a long time because you have to go through and first figure out, well, what is the tangent of u and what is the tangent of v? And then you have to plug in and then you have to simplify. So these are very long problems. Let's come back up here and let's first think about, well, we have the sine of u. The sine of u is equal to negative 7 over 25. Okay, well, how can I get the cosine of u? Well, I go back to my sine squared theta plus cosine squared theta equals 1. So we could just say that cosine squared u is equal to 1 minus sine squared u. So let's plug in a negative 7 over 25, and then we're going to square that. So negative 7 squared is 49, and then 25 squared is 625. So let's go ahead and say this is 49 over 625, and I'll say this is 625 over 625. So 625 minus 49, that's going to be 576. So let's say this is 576 over 625. Okay, let's come down here and think about this for a moment. Now we said that u and v are both in quadrant 3. So that means cosine is going to be negative. So the cosine of u is equal to the negative of, let me just say this is the square root of 576 over the square root of 625. Now we know the square root of 625 is 25. What about the square root of 576? Well, if you punch that into your calculator, it's actually going to be 24. So let's put this as 24 here. So the cosine of u is equal to the negative of 24 over 25. Now again, if you could spot this early, remember you have a 7, 24, 25 right triangle. Okay, so that's a special right triangle. Again, if you notice that, you can just plug in right away. If you don't, then you can just go through this. It's really not that big of a deal. So let's put this up here like this. And now I'm just going to say that my tangent of u is equal to the sine of u, which is negative 7 over 25, times the reciprocal of the cosine of u, which would be negative 25 over 24. So let's go ahead and cancel this with this. The negatives would cancel. So you have 7 over 24. So that's your tangent of u. Again, 7 over 24. Okay, let's grab this real quick. And I'm just going to paste this in here. And we'll use this in a moment when we come back. Let's come back up. I'm going to get rid of this information. We don't really need it anymore. And I'm going to think about the sine of v now. So again, if you notice that the cosine of v is equal to negative 4 over 5, again, for the sine of v, if you think about your Pythagorean triples, again, it's a 3, 4, 5 right triangle. So immediately I know, because I'm in quadrant 3, sine is negative, this is going to be negative 3/5. But again, if you want to go through it, you can. You can just say that you have sine squared v is equal to 1 minus cosine squared v. So plug in negative 4/5 and square that. You would get 16 over 25. And I think we've done this a million times in this course at this point. So this is 25 over 25. 25 minus 16 is 9. So this is 9 over 25. And then basically, because sine is negative in quadrant 3, we would say the sine of v is equal to the negative of the square root of 9, which is 3, over the square root of 25, which is 5. So it's just negative 3/5. So however you want to do it, a little bit quicker if you realize that you have a special right triangle there, but either way. So now the tangent of v is going to be equal to, again, take your sine of v, which is negative 3/5, multiply by the reciprocal of the cosine of v, which is negative 5/4. So let's go ahead and cancel this with this, and the negatives would cancel. So the tangent of v is going to be 3/4. Let's paste this in here real quick, and I'm just going to plug in. So for the tangent of u, this is going to be 7 over 24. Let's plug that in over here as well. And then for the tangent of v, this is going to be 3/4. Let's plug that in there, and then also there. Okay, let's get rid of this. Okay, how I would simplify this is to multiply first. And because you have 24 and 4 here, and then here you have 24 times 4, what I would do is just multiply without canceling. I know you can cancel between here and here, a common factor of 3, but just leave it alone. So 7 times 3 is 21, and this is over. 24 times 4 is 96. So now what you can do is actually multiply by 96 over 96, and that's going to clear all the denominators. So I'm going to put this in here, and then here, and then here, and then here. So let's say this is equal to 96 divided by 24. That's going to give me 4, and then 4 times 7 is 28. And then minus 96 divided by 4 is 24, and then 24 times 3 is 72. And this is over. 96 times 1 is just 96. And then plus the 96s would cancel, so you just have 21. So let's just crank out this simple arithmetic. So 28 minus 72, that's going to be negative 44. And this is over. 96 plus 21, that's going to be 117. So let's just move the negative out in front and say this is negative 44 over 117. And let's go back up. And I'm looking for this answer right here. So negative 44 over 117. All right, let's take a look at question 16. We want to find the exact value. We are given that the tangent of theta is equal to the square root of 111 over 17. We know that theta is in quadrant 1, and we want to find the cosine of 2 theta. So let's grab this, and come down here. If we go back to the handout for double angle identities, again, for the cosine of, let's say, 2a, you have 3 different formulas you can use. So I am going to choose to find cosine of, in this case, it's theta, but in the formula, it's a, right? So cosine of 2a is equal to 2 times cosine squared a minus 1. Now, the way we're going to figure this out, if you go back to the Pythagorean identities, again, we have tangent. So tangent squared theta plus 1 is secant squared theta. And again, if you solve for secant of theta, and then you find the reciprocal of that, you'll have your cosine of theta. So let's say that tangent squared theta plus 1 is equal to secant squared theta. And then I'm just going to plug in for the tangent of theta. So let's plug in this square root of 111 over 17, and then we're going to square that. So this would give me 111 over 289. So this is 111 over 289. Okay, if I'm adding 1, then what I can do is just add 289 over 289. So I have a common denominator. So 289 plus 111, that's going to be 400. So let me get rid of this and say this is 400 over 289. Now let me flip this around and say that we have secant squared theta is equal to 400 over 289. Okay, let me get rid of this. And again, we said that theta was in quadrant 1, so all the functions are positive. So we'll go ahead and say that the secant of theta is equal to the principal square root of this guy. So you could say the square root of 400, which is 20, over the square root of 289, which is 17. So that is my secant of theta. But again, what I want is the cosine of theta. So we're going to say that the cosine of theta is the reciprocal of this. So it's 17 over 20. Okay, now that we have this, we can plug into the formula. So cosine of 2 theta is equal to 2 times cosine squared theta minus 1. So my cosine of theta is 17 over 20. So let's plug that in here. And then we want to square that. So if I square 17, I get 289. If I square 20, I get 400. So this is 289 over 400. And then let's cancel a common factor of 2 between here and here. So this would be 200 now. So let me actually just write this down here and say that the cosine of 2 theta is equal to, this would be 289 over 200. And then minus, for 1, I'll write that as 200 over 200. And then we'll do 289 minus 200, and that's just going to be 89. So let's just say this is 89 over 200. So coming back up, I'll just paste this in. So the cosine of 2 theta is 89 over 200. So looking through my answers, I want this one right here, the 89 over 200. Okay, let's take a look at question 17. We're asked to find the exact value. Let's say we have negative 4 times this quantity. You have the sine of 195 degrees. Minus the sine of 75 degrees. Let me grab this real quick and come down here and paste this in. So there's a few different ways you could go about doing this. I think what I'm going to do is say this is negative 4 times. I'm going to have some parentheses here. And for the sine of 195 degrees, let's just say this is the sine of, I'll break this up into 150 degrees and then plus 45 degrees. 150 degrees and 45 degrees, they're both on the unit circle. And then we're going to go minus. You have the sine of, for 75 degrees, let's say that's 45 degrees plus 30 degrees. So again, both on the unit circle. And let's close this down. All right, let's see what we're going to run into here. So you could figure out what this is and replace it, and figure out what this is and replace it, and then do the subtraction. But I think it's probably going to be better, or at least give us more practice, if we do it a different way. So let's say this is negative 4 times. I'm going to open the parentheses here. I'm not going to be able to close them till way down here. So I'm going to start with the sum identity for sine. So we're going to go sine of 150 degrees, and then times the cosine of 45 degrees. And then this is a plus. You're going to have the cosine of 150 degrees, and then times the sine of 45 degrees. So that's this part right here. Now you have minus this whole thing, okay? So what you want to do is put minus, and I'm going to open up some other parentheses here. Again, I still have this bigger set from here. I'm not going to close that down yet, so I'm just working with this now. So inside of here, I'm going to go sine of the first guy, so 45 degrees, times the cosine of the second guy, which is 30 degrees. And then plus, now you're going to have the cosine of 45 degrees, the first guy, times the sine of the 30 degrees, the last guy. So close that down. And now I'm going to close this guy down. So I know this takes up multiple lines, but just if you're writing this on a piece of paper, maybe you can write really small and fit this on one line. It's just impossible for me to do. So let's calm it down here a little bit and think about this. Okay, so we have -4 times. You're going to have the sine of 150 degrees. And so I think we know at this point that that is the same as the sine of 30 degrees. So that's going to be a half. So this is 1/2 times the cosine of 45 degrees, which is the square root of 2 over 2. And then plus the cosine of 150 degrees. Well, again, the cosine of 30 degrees is square root of 3 over 2, but you're in quadrant 2, so it's negative. So this is the negative of the square root of 3 over 2. And then the sine of 45 degrees is going to be the square root of 2 over 2. And then minus, again, here's where you have this other set of parentheses because this negative here has to be distributed to each. So you have the sine of 45 degrees. Let me scooch down here a little bit. That's going to be the square root of 2 over 2. And then times the cosine of 30 degrees. That's going to be the square root of 3 over 2. And then plus the cosine of 45 degrees is going to be the square root of 2 over 2. And then times the sine of 30 degrees, which is 1/2. So I'm going to close this one down. And then again, I'm going to close this one down. Okay, so these parentheses here are for this negative here to be distributed. And then these parentheses here are for this -4 to get distributed. So it's important to recognize that. Again, if you're writing this on one line, it's easier to see. So let's scooch down a little bit here and think about what we have. So we have this -4 out in front. And then I'll just say that this is square root of 2 over 4. And then this is a negative times a positive, which is negative. So let me write minus square root of 3 times square root of 2 is square root of 6 over 4. And then we have minus whatever this ends up being. So let me wrap it in parentheses for now. And we'll say square root of 2 times square root of 3 is square root of 6 over 2 times 2, which is 4. And then we basically have plus square root of 2 times 1 is going to be the square root of 2 over 2 times 2, which is 4. So let me close this down. And let me switch colors back to this one and close this down. Okay, it looks like we're getting somewhere. I'm going to say this equals -4 times. Let's write the square root of 2 over 4, then minus the square root of 6 over 4. Then I'm going to distribute this negative to each. So this is minus the square root of 6 over 4. And then this is minus the square root of 2 over 4. Okay, let me close this down. So inside of the parentheses, I want you to notice that you have square root of 2 over 4 and negative square root of 2 over 4. So those two guys are actually going to cancel away. You'll say this minus this would be 0. So what you're going to end up with here is this -4 times you have negative square root of 6 over 4, and then you have minus square root of 6 over 4. So that's -2 times square root of 6 over 4. And you can see that this 4 would cancel with this 4. And so you basically can think about this as a -1 times a -2, which is a +2, and then times the square root of 6. So the answer here is 2 times square root of 6. So coming back up, I want this one. So 2 times the square root of 6. All right, let's take a look at question 18. So we want to find the exact value. We have the sine of 157.5 degrees. So again, for this one, I would use the half angle formula. Let me just write this out to the sine of 157.5 degrees. Let's grab this real quick and come down here. So if you want to use that half angle formula, the first thing you'll do is just double this. So 157.5 degrees times 2, that's going to give you 315 degrees. So this would be the sine of 315 degrees over 2. Okay, so this allows us to use our half angle formula. In case you forgot, if you have the sine of a over 2, it's equal to plus or minus the square root of 1 minus the cosine of a over 2. Now in this case, we are working with this angle that's 157.5 degrees. So always think about this. Don't think about this. So what am I trying to find the sine of? So this guy's in quadrant 2, so sine is positive. So I want the principal square root of 1 minus the cosine of this angle right here. This guy that's 315 degrees. So think about that. That is in quadrant 4, and you have a 45-degree reference angle. So cosine is positive in quadrant 4. Right? So the cosine of 45 degrees is square root of 2 over 2. So that means the cosine of 315 degrees would also be the square root of 2 over 2. And then this is over 2 down here. So let's put this as times 2 over 2. And I'm going to distribute this in here, and this goes here. And let's see what we're going to have. So this would be the square root of 2 times 1 is 2. and then minus the 2's would cancel, so you have the square root of 2, and then over 2 times 2 would be 4. Now you can break this up and say this is the square root of 2 minus the square root of 2 over the square root of 4. So we can say that this is the square root of 2 minus the square root of 2 over the square root of 4 is 2. So let me grab this, and we'll come back up here and just paste this in, and we'll look for this answer. So it looks like this guy right here. So we have the square root of 2 minus the square root of 2, and this is over 2. Okay, let's look at question 19. So we have that tangent of x. So the tangent of x, let me write that this is y over x, so we remember this is equal to 4 over 3. Now, x is in quadrant 1. So that means that y is going to be 4 and x is going to be 3. So if you want to find the cosine of x, remember it's just going to be x over r. And I think all of you know at this point that r is 5, right? This is a 3, 4, 5 right triangle. But once again, we can go through it and just say that r, it's equal to the square root of x squared. Again, x is 3, so 3 squared is 9, plus y squared. Y is 4, so 4 squared is 16. 9 plus 16 is 25. The principal square root of 25 is 5, so r is 5 there. Okay, so the cosine of x is going to be 3/5. Now, if I want to find the cosine of x over 2, again, just plug into your formula. So here's the cosine of a over 2. You have plus or minus the square root of 1 plus the cosine of a over 2. So let me slide this down here real quick. And I'll say this is plus or minus the square root of 1 plus the cosine of, in this case, it's x we're working with, so it's going to be 3/5. And then this is over your 2. Now, do I want plus or minus? Now, to figure that out, x is in quadrant 1. So you could say x is greater than 0 degrees and less than 90 degrees. And basically, you could just divide this by 2 to get your x over 2. So this is divided by 2, and this is divided by 2. So basically, your x over 2 is greater than 0 degrees and less than 45 degrees. So you know you're still in quadrant 1. So you want your principal square root here. All right, so now I would multiply this by 5 over 5. And then 5 gets distributed here and here, and then also here. And I kind of cut that off. That's a 3 there. So let's put that there. And so this is going to be the square root of 5 plus, the 5's would cancel, so this is 3, over 2 times 5 is 10. So 5 plus 3 is going to be 8. This is 8 over 10. And they're each divisible by 2, so 8 divided by 2 is 4. And then 10 divided by 2 is 5. So this is the square root of 4/5. Let me get rid of all this intermediate work. Get rid of all this, and I'm going to write this as the square root of 4 over the square root of 5. Let's get rid of this. Square root of 4 is 2. So all I have to do now is rationalize the denominator. So this is times the square root of 5 over the square root of 5. So this equals 2 times square root of 5 over 5. So coming down here, I want this. So 2 times square root of 5 over 5. All right, let's take a look at question 20. So first off, we're given that the tangent of x is equal to negative 15 over 8. Then we're told that x is in quadrant 2. So let me write that x is greater than 90 degrees and less than 180 degrees. And we want to find the cosine of x over 2. All right, let me grab this real quick. All right, so lots of different ways that you could go about solving this. Remember, the cosine of x over 2 is equal to plus or minus the square root of 1 plus the cosine of x over 2. So we're going to be using that identity. Now, we need to know the cosine of x. Lots of ways to do this. You could say tangent squared x plus 1 equals secant squared x. Solve that for the secant of x, and then take the reciprocal, and you'd have the cosine of x. It's probably quicker here to just realize that, again, you're working with a special right triangle. So this guy is going to be an 8, 15, 17 right triangle, right? So the r value here is 17. So in other words, if you said that this is the tangent of x is equal to, this will get a little confusing. So let me write the tangent of theta is y over x. Remember, this is the y coordinate from that point on the terminal side. This is the x coordinate from that point on the terminal side. It gets confusing if you put x there because x there is the angle that you're working with, and then x here again is the x coordinate from that point. So to not confuse you, I'm going to temporarily use theta. Okay, and so in this particular case, the y value is 15 because we're in quadrant 2, right? Y values are positive, and the x value is negative 8. So you can say that x is negative 8 and y is 15. And again, if you want to figure out the r value, a lot of you, again, know immediately that this is going to be 17. But you can just say that r is equal to the square root of x squared, so negative 8 squared would be 64, plus y squared, 15 squared is 225, and 64 plus 225, that's 289. And again, if you take the principal square root of that, you are going to get 17. Okay, so we know that r is 17 there. And so let me erase this, and now we want the cosine of x. And again, just take your x value and put it over your r value. And I know this gets confusing because you have an x right there, and a lot of people are going to go, what are you talking about? So again, this is the angle. It's just like if I said, what is the cosine of theta? Okay, so we're just using x in this place, and it's just the x value from here, which is negative 8, over the r value, which is 17. Okay, and you could put the negative out in front if you want. Okay, so now that we have that, we're basically home free. Okay, let me actually get rid of this, and you can divide everything here by 2 just to see where x over 2 is going to be. So this is going to be 45 degrees over here, and then over here this is going to be 90 degrees. So that tells me that we're going to be in quadrant 1, right? X over 2 is greater than 45 degrees and less than 90 degrees, so I'm in quadrant 1. So I'm going to adjust my formula and use the principal square root here. Let's move this down over here. So the cosine of x, we know, is the negative of 8 over 17. And what I'll do is just multiply this numerator and denominator by 17. So this is going to give me 17 minus 8. So 17 minus 8 over 34. Okay, so 17 minus 8 would be 9. So you basically have the square root of 9 over 34. So this would be the square root of 9, which is 3, over the square root of 34. Nothing I can really do with that. That's just 17 times 2. So I'll just rationalize the denominator and say this is times the square root of 34 over the square root of 34. And so this will be 3 times the square root of 34 over 34. So let me cut down all of this so I can make it more condensed. And I'll move this down here, and we'll just grab this, and I'll just paste this in here. So I'm looking for an answer for cosine of x over 2 to be 3 times square root of 34 over 34. All right, let's take a look at the quiz. For the first question, we're asked to find the exact value, and we want to find the inverse cosine of 0. So let me grab this real quick, and let's come down here. A lot of you already know that the answer is going to be pi over 2, but just in case you're struggling, let's first think about what is the range for something like y is equal to the inverse cosine of x. And I know we've talked about this a lot, but what is the range here? Well, it's going to be from 0 to pi, where 0 and pi are both included. So you're going to think about working from 0 to pi. So right here. Now, you would ask yourself the question, where is the cosine value going to be 0? Well, here I see an x-coordinate of 0, and that's going to occur right here at pi over 2. So what you can say is that the cosine of pi over 2 is equal to 0. And so the inverse cosine of 0 is going to be pi over 2. Now, again, the confusion comes up because you have the cosine of 3 pi over 2 is also 0. So a lot of students will ask, how come when I take the inverse cosine of 0, I'm not getting the 3 pi over 2 as well? Remember, the answer has to be within the range of the inverse cosine function. So if I ask for the inverse cosine of 0, I have to get the pi over 2 answer because it has to be from 0 to pi, where 0 and pi are included. So coming back up, I want to answer pi over 2. All right, let's take a look at question 2. So we're asked to find the exact value. And so here we have the inverse sine of the cosecant of negative pi over 2. So let's grab this real quick, and let's come down to the unit circle. So a lot of you know that this is a very easy problem. First, you would work on the inside. So you would say, what is the cosecant of negative pi over 2? And that's going to end up being negative 1. And then you take the inverse sine of negative 1, and that's negative pi over 2. But let's go step by step here. First off, what is the cosecant of negative pi over 2? Well, a lot of you can see that that is coterminal with 3 pi over 2. In other words, if I start here and I rotate clockwise by pi over 2, that gives me an angle of negative pi over 2. Well, of course, just looking at it, it's coterminal with 3 pi over 2. If you wanted to do that the long way, you could say it's the cosecant of negative pi over 2, and then plus, you want to add 2 pi. So in other words, if you were right here, at negative pi over 2, what you would do is you would add 2 pi. So I would swing around by 2 pi, put myself right back there, and I'd be at 3 pi over 2. So let me add 4 pi over 2, and this would give me the cosecant of 3 pi over 2. And then to think about that, let me get rid of all this. You would think about this as 1 over the sine of 3 pi over 2. And what's the sine of 3 pi over 2? Well, you're going to have a y-coordinate here of -1 at 3 pi over 2. So this is going to be 1 over -1, which is -1. So we see that the cosecant of negative pi over 2 is -1. So let me get rid of this, and let's put this equals the inverse sine of -1. And then what's the inverse sine of -1? Well, again, you've got to consider the range of the inverse sine function. So y is equal to the inverse sine of x for the range, we're thinking about from negative pi over 2 to pi over 2, with both of those guys being included. So in other words, I'm working from here to here. If I'm in this quadrant 4 here, I'm rotating clockwise. So you see that you have a sine value of -1 here, but again, the 3 pi over 2 is not 3 pi over 2, because again, I'm rotating clockwise. So that's that negative pi over 2 there. So what we would say, let me slide all this down here and put this right here, that this would be equal to negative pi over 2, because again, the sine of negative pi over 2 gives me -1, so the inverse sine of -1 is going to give me this negative pi over 2, because again, it's within this range for the inverse sine function. So let's come back up and say we want negative pi over 2. All right, let's take a look at question 3. So we want to find the exact value, and we have the inverse tangent of the sine of pi over 2. Okay, let's come down to the unit circle and think about this. So the first thing you want to do is find the sine of pi over 2. So you always work on the inside first. So here's pi over 2. The sine value is going to be 1. So this becomes the inverse tangent of 1. How do I find the inverse tangent of 1? Well, first off, where is the tangent value going to be 1? Well, it's going to be at pi over 4 and then 5 pi over 4. And that's coming from the fact that the tangent of something like, let's say, pi over 4 is equal to the sine of pi over 4, which is square root of 2 over 2, divided by the cosine of pi over 4, which is also square root of 2 over 2. So I'm going to multiply by the reciprocal, so times 2 over the square root of 2. We know at this point that the same non-zero number divided by itself is 1. So of course, let's go ahead and cancel things so we can show this. So this equals 1. If you did the tangent of 5 pi over 4, again, you'd have the same non-zero number divided by itself, and you would get 1. So when I go to find the inverse tangent of 1, I'm not going to get the 5 pi over 4. I'm going to get the pi over 4 because, again, the answer has to be within the range of the inverse tangent function. So y equals the inverse tangent of x. Well, here for the range, we're going to go from negative pi over 2 to pi over 2. Now, these have to be excluded here because the tangent of negative pi over 2 and the tangent of pi over 2, that's going to be undefined in each case because the cosine value is 0 and you'd have division by 0, which is undefined. So when I give the answer here, the inverse tangent of 1, I want to answer pi over 4 because, again, that's within the range of the inverse tangent function. So coming back up, I want to answer pi over 4. All right, let's take a look at question 4. So we want to write as an algebraic expression in U. So here we have the tangent of, you have your inverse sine of, you have u over the square root of u squared plus 1. I'm just going to paste this in, and I'm going to go through the first part, or the setup, and then we're going to think about the domain and range of each part so that we can understand whether this would be undefined anywhere or not. So thinking about how we would set this up, you want to take the argument for the tangent function. So this guy right here, your inverse sine of u over the square root of u squared plus 1. You want to set that equal to some variable. It doesn't matter what it is. Typically I use u, but in this case that's used up already. So let me let w be equal to this right here. So the inverse sine of u over the square root of u squared plus 1. Once we've established that, then what we can do is say that the sine of this w here is equal to this right here. So that's going to be your sine value. So this is u over the square root of u squared plus 1. Now I want to remind you that when we think about the sine of some angle, let's just call it W, well, that's the opposite over the hypotenuse. So this right here is your opposite, and this right here is your hypotenuse. Now, when we think about the problem a little bit more deeply, well, since we made a substitution here, we're really just trying to find the tangent of W. So this is equal to what? For right now, let me write that this is the opposite over the adjacent. So we really need to figure out what is the adjacent. Now, before we do that, I want to think about this part right here more deeply with you. You can skip this if it confuses you or if you don't really care that much. But essentially, if we go back to the top here, I took this part right here, which is the u over the square root of u squared plus 1, and I graphed it as y equals x over the square root of x squared plus 1. So I just put an x in the place of u just for graphing purposes. And I have a little calculator. You can click on that link if you want. It'll take you straight to it. Or, of course, you can just type it into Desmos on your own. But you want to think about what is the domain and the range of that guy. And that's going to lead into a realization when we're plugging things in for the inverse sine function. So here you have a domain that's from negative infinity to positive infinity, so all real numbers. And the range is from -1 to +1, with those guys being excluded. So let me show you a screenshot of the graph. Again, you can type this in on your own. You don't have to go to it. You can just take it as a given. But essentially, you want to know that the domain for this guy is from negative infinity to positive infinity. Again, all real numbers. And the range, so basically the output values here, this is from -1 to +1, with those guys being excluded. Let's come back and think about this. So this right here is what I'm going to focus on. So I just told you that the domain for this is all real numbers. So that means I can plug in whatever I want for u in terms of real numbers. So a negative, 0, a positive, whatever I want. Then the range is from -1 to +1, but those values are excluded. So that means, let me just put a little border here. When I think about the inverse sine there, I'm going to be taking the inverse sine of values between -1 and +1, with those guys being excluded. Well, I know that for something like the inverse sine of x, that the range is going to be from -pi/2 to pi/2, with those guys being included. But that comes from the domain of -1 to +1, with those guys being included. Well, the fact is, here I cannot get a value of -1, and I cannot get a value of +1, because again, that's not in the range of this guy right here, which is being plugged in for the inverse sine function. So in other words, I'm not going to be able to say that I have the inverse sine of -1, which would lead to -pi/2. And I'm not going to be able to say that I have the inverse sine of +1, which would lead to pi/2. So that tells me that the result of this guy right here, taking the inverse sine of this, is going to give me a w, or an angle measure, that is between -pi/2 and pi/2, where those guys are excluded. So w is greater than -pi/2. Remember, it can't be -pi/2 itself, because this right here will never be -1. And then it's going to be less than pi/2. Again, it can't be pi/2 because this will never be +1. So that tells me that I'm going to be good to go in terms of this tangent of w, because the tangent of -pi/2 or the tangent of pi/2 is undefined, but we're never going to get to that. W is going to be greater than -pi/2 and less than pi/2, so we don't have to worry about this being undefined. So let's think about this right here using a little sketch, and I've already set that up. I'm not a really good drawer, so it's best to just do that ahead of time. So we want to find the opposite over the adjacent. Okay, so basically we see that the hypotenuse here, whether I sketch it this way in quadrant 1 or this way in quadrant 4, so in other words, in quadrant 1, this is if u is positive, and in quadrant 4, this is if u is negative. Well, the hypotenuse is the same either way. It's just the square root of u squared plus 1. So it's here or here. Then when you think about u, here it's positive, here it's negative. Well, the adjacent either way is going to be +1, because x values are positive in quadrants 1 and 4. Now, how do we get this? Again, all you have to do is think about the fact that if you don't know the adjacent, or the x, you can say that you have x squared plus, let's say your y is u, and this is going to be squared, so it doesn't really matter if it's positive or negative, and this equals your hypotenuse, that's going to be squared, so the square root of u squared plus 1, that's going to be squared. So basically you have your x squared plus y squared equals r squared. So that's all we're doing. So this right here, if you square this, this is going to undo this square root guy. And so all you have to do at this point is subtract u squared away from each side of the equation. This cancels and this cancels. You're going to get x squared is equal to 1. And again, we know that the x values are positive in quadrants 1 and 4, which is where we would be. So really, you just want the principal square root here. So x equals the principal square root of 1, which is 1. So that tells me that this side right here is going to be 1. So if I'm trying to find my tangent of w, again, the opposite over the adjacent, let me move this over here. This is going to be equal to, well, the opposite is always going to be u, and then the adjacent is always going to be 1. So this just equals u over 1, which is just u. So the tangent of w is going to be u. So let's come back up and just answer this. So u is what we want. All right, let's take a look at question 5. So here we're asked to find the exact value. So we have the sine of 2 times the inverse cosine of 1/5. Okay, let's come down here. I have a little identity already set up for us. Essentially, what you want to do, again, is just make a substitution. I'm going to let something like u be equal to, you're going to grab just this part right here. So the inverse cosine, of 1/5. And the reason you do that is because then you can say that the cosine of u is equal to 1/5. So since u is equal to the inverse cosine of 1/5, I can just replace it here. So let me say that I have the sine of 2u. And this is equal to, again, that's why I have this identity here. So the sine of 2 theta is equal to 2 sine of theta cosine of theta. Let me erase that and just say that this is equal to 2 sine of u and then cosine of u. Well, I already know that the cosine of u is 1/5. So let me say that this is equal to, I'm going to put 2 sine of u and then times 1/5. How do I get the sine of u? Again, going back to this being the x and this being the r, or you could say the adjacent over the hypotenuse, well, all I really have to do is say that I have x squared plus y squared is equal to r squared. Now, first off, I know that if the inverse cosine function has an argument that's positive, that angle is going to be in quadrant 1. So I know u is in quadrant 1. Let me put that u is in quadrant 1. So let me plug in for x. I know that's 1. Let me plug in for r. I know that's 5. So this becomes 1 squared, which is 1. This 5 squared is 25. Let me subtract 1 away from each side of the equation. And so you get y squared is equal to 25 minus 1, which is 24. Now, again, we're in quadrant 1, where y values are positive. So this gives me y is equal to the principal square root of 24. Now, you can simplify that. 24 is 4 times 6. And so the square root of 4 is 2. So this is 2 times the square root of 6. So knowing that, you want your y value over your r value. So for the sine of u, let me write this over here, the sine of u, this is your y value, which is 2 times square root of 6 over your r value. Let me slide all of this down. I think I'm going to mess this up. So let me rewrite this. So this is the sine of u, and I did that terribly. So one more time. So the sine of u, and this is in quadrant 1. Okay, so this is your y value over your r value, which is 5. So the sine of u is 2 times square root of 6 over 5. Let me get rid of this and write this in. So 2 times square root of 6 over 5. So this equals 2 times 2 is 4. So this is 4 times the square root of 6 over 5 times 5 is 25. So the answer here is 4 times square root of 6 over 25. So coming back up, I want this one. So 4 times square root of 6 over 25. All right, let's take a look at question 1. We want to find all solutions in degrees. And I have a little note here. All answers below are in degrees. So if you see something like 135 plus 360n, that's meant to be 135 degrees plus 360 degrees times n, where n is any integer. Okay, so let's start off by just copying this. So we have 15 plus the square root of 2 over 5, and then plus the cosine of theta. And this equals 3 plus 3/5 times the cosine of theta. So let's just grab this real quick, come down here and paste this in. I would start by multiplying everything by 5, so I can clear this denominator and this denominator. So you would have 15 plus the square root of 2 plus 5 times the cosine of theta is equal to 5 times 3 is 15, and then plus 3/5 times 5 is 3, so this is 3 times the cosine of theta. Okay, I want all the terms with cosine of theta on one side and everything else on the other. Now, what I noticed right away is you have 15 here and 15 here. You could just subtract 15 away from each side of the equation. That's going to go away. So let me subtract 3 times cosine of theta away from each side of the equation. Let me slide down here a little bit. So this will cancel away. And let me subtract square root of 2 away from each side of the equation. So that will cancel away. So let me write that we have 5 times cosine of theta minus 3 times cosine of theta. That is 2 times the cosine of theta. And this equals the negative of the square root of 2. All right, let me slide down here a little bit. I'm going to divide both sides of the equation by 2. So this cancels. You have the cosine of theta is equal to the negative of the square root of 2 over 2. All right, now most of you know that the square root of 2 over 2, forget about the negative of the square root of 2 over 2. If I do the inverse cosine of the square root of 2 over 2, or if I did the inverse sine of the square root of 2 over 2, I would get pi over 4 if I'm working with radians, or 45 degrees if I'm working with degrees. So let's go ahead and put 45 degrees. We were asked to work with degrees. Now, when I think about this, cosine is going to be negative when I'm going to be in quadrant 2 and 3, right? And 1 and 4, it's going to be positive. So that tells me I just want to go into quadrant 2 and find an angle with a 45-degree reference angle, and the same thing in quadrant 3. Now, if you know your unit circle, in quadrant 2, it's going to be 135 degrees, and in quadrant 3, it's going to be 225 degrees. But if you don't know that, you can go and say, okay, for quadrant 2, I can start with 180 degrees and subtract away 45 degrees. That would give me 135 degrees. Maybe I can make that a little bit better. And then for quadrant 3, you could start with 180 degrees and add 45 degrees, and that's going to give you 225 degrees. So this is what I'm looking for, 135 degrees and then 225 degrees. So coming back up here, when we think about all solutions in degrees, remember the period for cosine is 2 pi. So I'm going to start with this first solution, and I'm going to say 135 degrees plus 360 degrees times n. N is any integer. And then I'm going to put a comma and go 225 degrees plus 360 degrees times n, where n is any integer. So let me get rid of this and look through what we have. So it's going to be this one right here. So 225 plus 360n, that's what we have here. Remember, I put a note here that everything was in degrees. And then the other one is 135 plus 360n, that's what we have here. So this is what we want to give as an answer if we want to find all solutions in degrees. All right, let's look at question 2. And so we have 21 over 5 plus 2 times sine of theta is equal to 4 plus 12 over 5 times sine of theta. If you multiply everything by 5 here to clear the denominators, you would have 21 plus 5 times 2 is 10, so 10 times the sine of theta. And this equals 4 times 5 is 20 plus this getting multiplied by 5, the denominator is going to get cleared. So you would basically just have 12 times the sine of theta. I think we can actually fit this right here. So let me just try this right here. So minus 12 times the sine of theta, and then minus 12 times the sine of theta. That would cancel. And let me subtract 21 away from each side of the equation. That would cancel. So 10 times the sine of theta minus 12 times the sine of theta is going to be negative 2 times the sine of theta. And this equals 20 minus 21. That's going to be negative 1. Let me get rid of this. I think we can all see that the sine of theta is going to be 1/2. So that's pretty easy. Divide both sides of the equation by negative 2. This is going to cancel. So you get the sine of theta is equal to negative over negative is positive. So this is just positive 1/2. All right. I think most of us know off the top of our head, without even going to a unit circle, that the answer here is going to be pi over 6 if you're in the first quadrant, and sine is also positive in the second quadrant, so it would be 5 pi over 6. But here we're working with degrees, so I would say 30 degrees and then 150 degrees. So let me put theta is equal to 30 degrees and then 150 degrees. Now, we are asked for all solutions in degrees. So that means I've got to take this and add 360 degrees times n, where n is any integer. So let me put this like this and say 30 degrees plus 360 degrees times n, where n is any integer, and then 150 degrees plus 360 degrees times n, where n is any integer. So looking through my choices, I want this one right here. Again, if you're asked for all solutions in degrees, 30 plus 360n, so that's this right here, then 150 plus 360n, so that's going to be this one right here. All right, let's look at question 3. So we're asked to find all solutions in radians. So we have a -3 plus 2 times the tangent of theta is equal to -2 plus the tangent of theta. All right, so I'm just going to add 3 to both sides of the equation and subtract the tangent of theta away from each side of the equation. This one looks really, really easy. So this is going to cancel, and this right here is going to cancel. So you have 2 times the tangent of theta minus the tangent of theta. That's going to give me the tangent of theta. And this equals -2 plus 3 is going to be 1. So you have the tangent of theta equals 1. Now it wants all solutions in radians. So if I use my inverse tangent function, with 1 as the argument, I think all of us know you're going to get 45 degrees or pi over 4 because now we're working with radians. So it wants all solutions. Remember, the period for tangent or cotangent is pi. So basically all you'd have to do is say, well, this is going to be pi over 4. That's going to be from quadrant 1. And then I can add multiples of pi. So plus pi times n, where n is any integer. So that right there would be your general solution. So we're looking for this one right here, which is pi over 4 plus pi n. Again, where n is any integer. All right, for question 4, we are asked to find all solutions in radians. So we have the negative of the cosine of theta equals 4 minus 5 times the cosine of theta. So add 5 times the cosine of theta to both sides of the equation. This would cancel. And so negative cosine of theta plus 5 times cosine of theta would be 4 times cosine of theta. And this would be equal to 4. Now I would divide both sides of the equation by 4. This would cancel. And you get cosine of theta is equal to 1. So where is cosine of theta equal to 1? Well, remember, this is going to happen at 0 and then 2 pi and then 4 pi. Or you could say 0 and then -2 pi, -4 pi. So basically, you could give your solution as 0 plus the period of cosine is 2 pi. So 2 pi n. 0 plus anything is just itself. So you end up with this solution here for the general solution of 2 pi n. So this guy right there. All right, for question 5, we are asked to find all solutions in radians. So let me actually start by saying this is 3 minus 4 times the secant of theta. This equals 2 times the secant of theta. Let's see. Let me subtract 2 times the secant of theta away from each side of the equation. That would cancel away. Let me subtract 3 away from each side of the equation. That would cancel away. -4 times the secant of theta minus 2 times the secant of theta is going to be -6 times the secant of theta. And this equals -3. And let me divide both sides of the equation by -6. Let me get rid of that. And let me cancel this with this. And I would get the secant of theta is equal to negative over negative is positive. 3 over 6, that's going to be 1/2. You have that the secant of theta is equal to 1/2. So you can transform this over and say that this is the cosine of theta is equal to 2, right? Just take the reciprocal of this because the secant of theta is equal to 1 over the cosine of theta. Now, is this possible? Can you have the cosine of theta being equal to 2 or the secant of theta being equal to 1/2? No. Why is that the case? Remember, with the cosine function, the range is from -1 to +1. With the secant function, basically your y value is going to be -1 or anything less, or it could be +1 or anything greater. So neither of these is going to be possible. So you could just say that there's no solution. No solution, right? Because this is just nonsense. The cosine of theta can't be 2. The secant of theta can't be 1/2. So you would put no solution. All right, let's take a look at the quiz. For the first question, we're asked to solve the equation for theta is greater than or equal to 0 degrees and less than 360 degrees. And I have a note, all answers below are in degrees. So we're going to see that 2 times square root of 3 times the secant of theta cosine of theta plus 3 secant of theta is equal to 0. Now, what I'm going to do is actually factor out the secant of theta just to stay consistent with what we did in the lesson. But you also could notice that the secant of theta times the cosine of theta is 1. So if you did that, you would say 2 times the square root of 3 plus 3 secant of theta is equal to 0. Let me actually just solve this real quick, and then we'll come back up and do the factoring. Just in case you did it this way, I want to make sure you understand what's going on here as well. So we could subtract 2 times square root of 3 away from each side of the equation. This would cancel. You get 3 secant of theta is equal to -2 times the square root of 3. We would divide both sides of the equation by 3. So this would cancel. All right, let me actually erase this and erase this. We know that the cosine of theta, by definition, is 1 over the secant of theta. So if I want to put this in terms of cosine, I can just say that the cosine of theta is equal to, just take the reciprocal of this, so it would be negative, you would have 3 over 2 times the square root of 3. So let me get rid of this and get rid of this. And basically at this point you could simplify. So 3, you could write that as the square root of 3 times the square root of 3. And then I could cancel this square root of 3 with this square root of 3. So let me just erase that from here and here. And I'll just write this as the cosine of theta is equal to the negative of the square root of 3 over 2. So we're going to get the exact same thing from factoring. Let me just grab this real quick. And I'm just going to paste this in so that we have it. I'm going to come back up here and do this with factoring just to stay consistent with what we did in the lesson. So here I would just pull out the secant of theta. So let me put that out in front here. Inside the parentheses, you'd have 2 times square root of 3, and then times the cosine of theta, and then plus you'd have a 3, close down the parentheses, and this equals 0. Okay, so from the zero product property, we would say that the secant of theta is equal to 0, then or you would say that 2 times square root of 3 times cosine of theta plus 3 is equal to 0. Hopefully you know that the secant of theta equals 0. That has no solution. So this has no solution. When you think about the range of the secant function, again, remember, it's going to be from -1 going down to negative infinity, and then +1 going up to positive infinity. So there's no value you can plug in for theta there such that the secant of theta would give you 0. So there's no solution. For this one, we would subtract 3 away from each side. This cancels. You get 2 times square root of 3 cosine of theta is equal to -3. Let's divide both sides of the equation by 2 times square root of 3. And so this right here is going to cancel. I'm going to have the cosine of theta is equal to the negative of 3 over 2 times square root of 3. Now again, you could write 3 as the square root of 3 times the square root of 3. And then we can cancel this right here with this right here. So let me go ahead and erase this and erase this. And I'll say that this right here is the negative of the square root of 3 over 2. So we found that earlier, and we already have it here at our unit circle. So I'm basically just looking in quadrants 2 and 3, where cosine is negative, and I'm looking for an x-coordinate of negative square root of 3 over 2. So when I look through, I see one right here. So that's going to be at 5 pi over 6. Notice the reference angle is going to be pi over 6. And then if I go into quadrant 3, it's going to be 7 pi over 6. So right there, again, notice the reference angle is pi over 6. The reason I talk about the reference angle is we don't always have a unit circle handy. So maybe you just want to figure this out without one. So you could say inverse cosine of square root of 3 over 2, forget about the negative. That's going to give you pi over 6. And then you just say, okay, I know cosine is going to be negative in quadrants 2 and 3. So give me an angle in quadrants 2 and 3 with a reference angle of pi over 6. So that's going to give you 5 pi over 6 and 7 pi over 6. So we're going to put that in terms of degrees because that's what it asked for. So theta would be equal to, we're going to have 150 degrees and then also 210 degrees. So let me grab this real quick. So coming back up here, again, we're asked for this in degrees. We want to say it's going to be 150 degrees and then 210 degrees for theta being greater than or equal to 0 degrees and less than 360 degrees. If you want to work with radians, then you could say that it's 5 pi over 6 and then 7 pi over 6 for theta being greater than or equal to 0 and less than 2 pi. Okay, let's take a look at question 2. So here again, we want to solve the equation for theta is greater than or equal to 0 degrees and less than 360 degrees. I have here all answers below are in degrees. I'm going to add secant squared theta to both sides of the equation. That would cancel. And add 5 to both sides of the equation. So that would cancel. So the right side is going to be 0. So I'm going to write this as secant squared theta. And then we have plus 4 secant of theta. And then -1 plus 5 is going to be 4, so plus 4. Okay, let me clear this out. And let me say that this right here is going to be equal to 0. Let me grab this real quick and come down here and paste this in. Now this is something you can factor. So this right here would be secant of theta. And then this would be secant of theta. Remember, this is a 1 here, so that makes this obvious. Then you need two integers whose sum is 4 and whose product is 4. Well, that's going to be 2 and then 2, right? So plus 2 and then plus 2. So of course we can write this as the secant of theta plus 2 quantity squared and just set that equal to 0. Now, you can solve this in a few different ways. I'm just going to use the square root property, and I'm going to say the secant of theta plus 2 is equal to plus or minus the square root of 0, which is just 0. Let me get rid of this, and actually we don't need this anymore. So what I'll do here is just subtract 2 away from each side. This cancels. We're going to have that the secant of theta is equal to negative 2. And because we have our cosine values in the unit circle, let's just write this in terms of cosine. So I'll say the cosine of theta is equal to 1 over the secant of theta. So this is 1 over negative 2, or negative 1/2. So let me grab this, come down here and just paste this in. So cosine, again, is negative in quadrants 2 and 3. I'm looking for an x-coordinate of negative 1/2. So that's going to be right here at 2 pi over 3, or 120 degrees, and then also right here at 4 pi over 3, or 240 degrees. Again, if you don't have the unit circle, you can do the inverse cosine with positive 1/2. That would give you 60 degrees, and then just use that as your reference angle in quadrants 2 and 3, where cosine is negative, and that's going to give you the 2 pi over 3 and the 4 pi over 3, or 120 degrees and 240 degrees. We are asked for degrees here, so let me write that out. So theta is equal to 120 degrees, and then 240 degrees. So let me grab this. So coming back up here, where theta is greater than or equal to 0 degrees and less than 360 degrees, we'll say theta is equal to 120 degrees, and then also 240 degrees. So this guy right here. If you want to work with radians where your theta is greater than or equal to 0 and less than 2 pi, then you could say it's 2 pi over 3, and then also 4 pi over 3. All right, let's take a look at question 3. So we have solve the equation for theta is greater than or equal to 0 and less than 2 pi. So let me subtract 1 away from each side to get things started. This would be 0 over here. And I'm going to write out that we would have the sine squared theta, and then plus 2 sine of theta. And then 2 minus 1 is going to be 1. So plus 1, this equals 0. So let me actually erase this. And I'll just grab this and paste this in. This is something we can factor. So let me set this up real quick. This right here would be sine of theta, and this right here would be sine of theta. Again, this is a 1, so that makes that obvious. Then you need two integers whose sum is 2 and whose product is 1. Well, that's going to be 1 and 1. So again, you can make this a little bit simpler and say sine of theta plus 1 quantity squared. And we'll go ahead and say this equals 0. Lots of ways to solve it, but I'm just going to say that sine of theta plus 1 is equal to 0. So just using the square root property. So this guy right here is equal to plus or minus the square root of 0. The square root of 0 is 0, and the plus or minus, you can just get rid of it because it's 0. So let me subtract 1 away from each side. This cancels. Slide down here, and we'll say that the sine of theta is equal to negative 1. So we'll come down here and paste this in. So I'm looking for a y-coordinate on the unit circle of negative 1. So that's going to occur right here only. So that's at 3 pi over 2 in terms of radians, or 270 degrees if you want to work with degrees. So in that interval that we're given, there's only going to be one solution. So let's say theta is equal to 3 pi over 2. So coming back up, again, for theta is greater than or equal to 0 and less than 2 pi, we'll say theta is equal to 3 pi over 2. So this guy right here, again, if you want to work with degrees, where theta is greater than or equal to 0 degrees and less than 360 degrees, well, then your answer would be theta is equal to 270 degrees. All right, for question 4, we're asked to solve the equation for theta is greater than or equal to 0 and less than 2 pi. So let's write out 4 sine squared theta minus 4 sine of theta. And then I'm going to add 3 to both sides of the equation. So negative 2 plus 3 is going to be 1, and this would be equal to 0. So let me just erase this, and we'll grab this real quick and come down here and paste this in. So to factor this one, it could be 4 here and 1 here, because this is a 4, but it's more likely going to be 2 and 2. So let me start with 2 sine of theta and 2 sine of theta. And then I need to think about this last guy here is a plus 1, but this is a negative 4. Okay, well, that means that this is a plus 1, that this sign and this sign, it has to be the same. So either a negative times a negative or a positive times a positive. But this is a negative here, which is going to come in this particular situation from a negative plus a negative because the signs need to be the same. So I'm going to put a minus 1 here and a minus 1 here. So if you look at this to check, you'll see that this is negative 2 sine of theta. And this right here is negative 2 sine of theta. So basically, let's close this down like this and say this is 2 sine of theta minus 1 quantity squared. and this is equal to 0. And so again, from the square root property, we can say 2 sine of theta minus 1 is equal to 0. Add 1 to both sides. This would cancel. And you would say 2 sine of theta is equal to 1. Divide both sides by 2, and you'll get that the sine of theta is equal to 1/2. So this would cancel. So let's grab this, and let's paste this in. So where is the sine of theta equal to 1/2? Well, in quadrant 1, sine is going to be positive, so I'm looking for a y-coordinate of 1/2. So that's at pi over 6 or 30 degrees. Go into quadrant 2, and we're looking for a y-coordinate of 1/2. So that's at 5 pi over 6. Again, notice the reference angle is pi over 6 there. So we can come back up and just say that theta is equal to pi over 6 and then 5 pi over 6. Again, this would be in your interval where theta is greater than or equal to 0 and less than 2 pi. So I'm just going to select this answer right here. Again, in terms of degrees, if theta is greater than or equal to 0 degrees and less than 360 degrees, then you'd want to say 30 degrees and then 150 degrees. All right, let's take a look at question 5. So now we want to solve the equation for theta is greater than or equal to 0 and less than 2 pi. We are given square root of 3 tangent of theta plus 3 tangent squared theta equals 2 tangent squared theta. Okay, so to think about this, let me subtract 2 tangent squared theta away from each side of the equation. That would cancel and give me a 0 over here. So 3 tangent squared theta minus 2 tangent squared theta, that's tangent squared theta. So let me put that out in front. So tangent squared theta, and then plus this square root of 3 tangent of theta, this equals 0. Let me actually erase this, and I'm just going to grab this and come down here. And let's think about factoring. I'm going to pull out a tangent of theta. So let me rewrite this to make this crystal clear as the tangent of theta times the tangent of theta. So I'm going to pull this out and this out. So put that out in front of some parentheses. You'll have the tangent of theta out here. Inside, you'll have the tangent of theta plus you'll have the square root of 3. And then close that down. Let me make that a little bit cleaner there. And this would be equal to 0. So to solve this, you would say that the tangent of theta is equal to 0, or you would say that the tangent of theta plus the square root of 3, let me slide this over here, is equal to 0. So for this one, just subtract the square root of 3 away from each side. So the tangent of theta would be equal to the negative of the square root of 3. So let me grab this. So the first one's pretty easy. For the tangent of theta to be equal to 0, remember that the tangent of theta, by definition, is the sine of theta over the cosine of theta. So you need the sine of theta to be 0 and the cosine of theta to not be 0. So looking for the sine of theta to be 0, you see that here at 0. And then also you see that here at pi. Now for the tangent of theta to be equal to the negative of the square root of 3, again, you can always just use your calculator in the inverse tangent function. If you punch in just square root of 3, that's going to give you pi over 3. Again, if you look at this guy right here at pi over 3, well, if you did the sine value divided by the cosine value, let me get rid of this real quick. If I did tangent of pi over 3, that's going to be the sine value, which is square root of 3 over 2. That's coming from this y-coordinate here, divided by the cosine value. So I'm just going to multiply by the reciprocal. So multiply by 2. Those would cancel. So the tangent of pi over 3, you're just going to get the square root of 3. Now, I want something where tangent is going to be negative. So what angle in quadrant 2 has a reference angle of pi over 3? Well, it's going to be 2 pi over 3. Again, you can always do pi minus your reference angle of pi over 3. So this is 3 pi over 3 minus pi over 3. That's 2 pi over 3. So that's one way you can figure it out if you can't see it from the unit circle. I also want to go into quadrant 4 and again find an angle with a reference angle of pi over 3. So that's going to be 5 pi over 3 right there. Once again, you could do 2 pi minus your reference angle of pi over 3. So this would be 6 pi over 3. 6 pi over 3 minus pi over 3 is 5 pi over 3. Again, it's easier just to look at it on the unit circle, but you don't always have that available. So looking at the solutions here, it seems as though we're going to have 4 of them. So let's say that theta is equal to, we have 0, and then 2 pi over 3. Then we have pi, and then lastly, we have 5 pi over 3. Let me paste this in here and let me look for the solution. Again, this is for theta being greater than or equal to 0 and less than 2 pi. So I'm looking for this guy right here. So you have 0, 2 pi over 3, pi, and then 5 pi over 3. If you're working with degrees where theta is greater than or equal to 0 degrees and less than 360 degrees, you would say you have 0 degrees, 120 degrees, 180 degrees, and then 300 degrees. All right, let's take a look at the quiz. For the first question, we're asked to solve each for theta is greater than or equal to 0 and less than 2 pi. We are given -2 minus 4 cosine squared theta is equal to -3 minus 3 cosine squared theta. All right, what I would do here is add 3 cosine squared theta to both sides of the equation. So that's going to cancel away from over here. And then I would add 2 to both sides of the equation. So that's going to cancel away over here. So that's going to give me -4 cosine squared theta plus 3 cosine squared theta. That would be -1, or you could just say negative cosine squared theta. And this would be equal to -3 plus 2. That's going to be -1. So what I would do is multiply both sides by -1, and you would have cosine squared theta equals 1. From the square root property, we can basically just say that this is the cosine of theta is equal to plus or minus the square root of 1. The square root of 1 is 1, so it's just plus or minus 1. So that means that I want the cosine of theta is equal to 1, or the cosine of theta is equal to -1. So let me grab this real quick, and let me paste this in here like this. So if I look for where the cosine of theta is 1, again, the x-coordinate would need to be 1. That's going to be right there, and that's going to be at 0 in terms of radians, or 0 degrees. And then where is cosine of theta equal to -1? Well, that's going to be right here, so at pi, or 180 degrees. So coming back up, I'll say that theta is equal to 0 or pi. Again, this is in the interval where theta is greater than or equal to 0 and less than 2 pi, so this guy right there. All right, for question 2, now we want to solve each for theta is greater than or equal to 0 and less than 2 pi. And we have cosecant squared theta minus 1 is equal to 0. So just add 1 to both sides and say that you have cosecant squared theta is equal to 1, which basically turns into cosecant of theta is equal to plus or minus the square root of 1, which is 1. Now what I'll do is put this in terms of sine of theta. So the sine of theta is equal to 1 over the cosecant of theta. So basically, you would say that the sine of theta is equal to 1, or the sine of theta is equal to -1. Because if you had cosecant of theta equals 1, well, 1 over 1 is 1. If you had cosecant of theta equals -1, well, 1 over -1 is -1. So that turns into sine of theta equals 1, or sine of theta equals -1. So coming down to the unit circle, again, we're thinking about, well, where is the y-coordinate 1? Well, that's going to be at pi over 2 or 90 degrees. Where is it -1? Well, that's going to be at 3 pi over 2 or 270 degrees. So coming back up here, again, in this interval where theta is greater than or equal to 0 and less than 2 pi, we'd say theta is equal to pi over 2, and then also 3 pi over 2. So looking through the answers, I want this one. So pi over 2 or 3 pi over 2. All right, for question 3, again, we want to solve each for theta is greater than or equal to 0 and less than 2 pi. So we have cosecant of theta plus cotangent squared theta is equal to 1. So you have cosecant of theta and cotangent squared theta. Maybe that could be written a little bit better there. Let me come down here to this little Pythagorean identity that hopefully you know at this point. So I have cotangent squared theta. So I can just plug in for that. Let me come back down here. I'm going to solve for cotangent squared theta, and it doesn't matter that this is x and this is theta. And this equals, I'm going to subtract 1 away from each side, so cosecant squared theta minus 1. So these are the same, so that means I can take this right here and plug it in for that right there. So what I'll say is that the cosecant of theta plus, again, I'm plugging this in for cotangent squared theta, so cosecant squared theta minus 1 is equal to 1. And so now what I'm going to do is subtract 1 away from each side. So this would be minus 2 over here, and this would be 0 over here. When you get something in this form, let me rewrite this. So cosecant squared theta plus cosecant of theta minus 2 equals 0. Try to factor it. If you can't factor it, you can use the quadratic formula, but this is going to be factorable. Most of the problems you get are factorable. So this would be cosecant of theta, and this would be cosecant of theta. And then basically, you need two integers whose sum is 1 and whose product is negative 2. So what you could do is positive 2 and then negative 1. So let me get rid of this. And I'm going to say that the cosecant of theta plus 2 is equal to 0, or the cosecant of theta minus 1 is equal to 0. So this, if I subtract 2 away from each side, becomes cosecant of theta is equal to negative 2. Then, or you're going to have cosecant of theta, if I add 1 to both sides, is going to be equal to 1. Okay, let me come to the unit circle. Now, of course, we don't have cosecant values on the unit circle, so you can just convert things over into sine. So remember that the sine of theta is equal to 1 over the cosecant of theta. So I could say the sine of theta is equal to 1 over negative 2. So this is negative 1/2. And then I could say, or the sine of theta is equal to 1 over 1 would just be 1. So let me get rid of this. And let's look for other solutions. We know sine is negative in quadrants 3 and 4. So where's the y-coordinate? Negative 1/2. So they're at 11 pi over 6. And then also, it's going to be here at 7 pi over 6. So basically, in quadrants 3 and 4, where you have angles that have a reference angle of pi over 6. And then sine of theta equals 1. Well, where's the y-coordinate 1? Well, that's going to be at pi over 2. So let's write down the solution. So theta is equal to, let's start with pi over 2. And then let's go to 7 pi over 6. And let's go to 11 pi over 6. So let's grab this real quick. Come back and paste this in. So I want this answer right here. So pi over 2, 7 pi over 6, and 11 pi over 6. All right, let's take a look at problem 4. So we want to solve each for theta is greater than or equal to 0 and less than 2 pi. So we get 2 cotangent of theta minus cosecant squared theta is equal to 0. In the last example, we saw we had cotangent squared theta in the problem, and so we solved this for cotangent squared theta, and we found that cotangent squared theta was equal to cosecant squared theta minus 1. Well, here, notice that you have this minus cosecant squared theta. So I have cosecant squared theta right here. I don't have negative cosecant squared theta, but I have cosecant squared theta. So what I'm going to do is plug in for that. So let me move this down like this. And we have to be very careful here because we have a minus in front of what we're going to plug in for. So we're going to plug in a 1 plus cotangent squared theta for cosecant squared theta right here. So let's go 2 cotangent of theta, then minus. Here's where you got to be really careful. I'm going to put some parentheses here because the whole thing needs to be subtracted away. So 1 plus cotangent squared theta. Okay, close that down, and this equals 0. If you don't put the parentheses there, you're going to make a sign mistake, and it's going to throw the whole problem off. So it's very, very important. So let's come down here, and we're going to say that this is 2 cotangent theta, and then this is going to get distributed to each guy. So minus 1, and then minus cotangent squared theta, and this equals 0. So I would just rearrange this for right now. So minus cotangent squared theta, and then plus 2 cotangent of theta, and then minus 1 equals 0. To make it easier to factor, I would multiply everything by negative 1. So let's say this is positive, this is negative, and then this is going to be positive, and there's no change on 0. So I just multiplied everything by negative 1. So now I can factor this pretty easily. And so this guy is a 1 here, so this becomes cotangent of theta, and this is cotangent of theta. Now give me two integers whose sum is negative 2 and whose product is positive 1. Well, that's going to be negative 1 and negative 1. So this right here can be written as the cotangent of theta minus 1 quantity squared is equal to 0. So to solve this, you just say cotangent of theta minus 1 is equal to 0. And then I can add 1 to both sides, and you get cotangent of theta is equal to 1. Remember, the tangent of theta is equal to 1 over the cotangent of theta. So I could also say that the tangent of theta is equal to 1. So let's come down to the unit circle and think about tangent of theta equals 1. Again, we've seen this many times. We know that at pi over 4, the sine value is square root of 2 over 2, and the cosine value is square root of 2 over 2. So the same non-zero number divided by itself is going to be 1. And the tangent of theta is the sine of theta divided by the cosine of theta. Now, additionally, you could go into quadrant 3, where tangent is positive, and you can look for an angle with a reference angle of pi over 4. So that's going to be 5 pi over 4. You could also say the period of tangent is pi, so I can swing around from this point right here by pi radians, or 180 degrees, to get to the next solution there, which would be 5 pi over 4, so another way to think about it. If you look at it here, you'd have the same non-zero number divided by itself, so you would get 1 as well. So I would say that theta is equal to pi over 4, and then also 5 pi over 4, given that we're having a theta that's greater than or equal to 0 and less than 2 pi. So we're going to want this one right here. So theta is pi over 4 or 5 pi over 4. All right, for question 5, we're asked to solve each for theta is greater than or equal to 0 and less than 2 pi. So we have the cosecant of theta is equal to the square root of 2 times the cotangent of theta. What I would do in this case is square both sides. So square this side and square this side. Now, the downside to this is you have to check your solutions when you square both sides of an equation, but this becomes cosecant squared theta, and this would be equal to, you would have the square root of 2 squared times the cotangent of theta squared. So the square root of 2 squared is 2, and then this is just written as cotangent squared theta. So 2 cotangent squared theta. So I'm going to plug in for cosecant squared theta. If we come back, remember, cosecant squared theta is equal to 1 plus cotangent squared theta. So I'm just going to erase this and put this in. So 1 plus cotangent squared theta. So what I would actually do is subtract cotangent squared theta away from each side of the equation. And so that is going to give me 1 is equal to cotangent squared theta. Let me get rid of this. And of course, using the square root property, you would say the cotangent of theta is equal to plus or minus the square root of 1. So that's plus or minus 1. Now what I would do is convert this over into tangent, because again, the tangent of theta is equal to 1 over the cotangent of theta, and it's going to be the exact same thing. So the tangent of theta here would be equal to 1, or the tangent of theta is equal to negative 1. So we can go to the unit circle and think about this. So the tangent of theta equals 1, or the tangent of theta equals negative 1. So we already saw this in a previous problem, that for the tangent of theta equaling 1, well, that's going to happen at pi over 4, and then also at 5 pi over 4. And then for the tangent of theta being equal to negative 1, well, I just want to go into quadrants 2 and 4, where tangent is negative, and find an angle with a reference angle of pi over 4. So that would be here at 3 pi over 4, and then here at 7 pi over 4. Okay, so we have our proposed solutions, but they're not necessarily going to work because we squared both sides of the equation. So we have to check. I'm just going to grab this equation. So cosecant of theta is equal to the square root of 2 times the cotangent of theta. Now you want to check, let me put a little border here. Theta is equal to, you have pi over 4, you have 3 pi over 4, you have 5 pi over 4, and you have 7 pi over 4. So those are proposed solutions. They're not necessarily going to work because, again, we squared both sides of an equation. So I would go through and figure out what is the cosecant of each value here. It's just going to make it a lot quicker. And basically, where cosecant is positive, so in quadrants 1 and 2, so for pi over 4 and 3 pi over 4, you'd have the same value. So the cosecant of pi over 4, and then I'll put a comma, the cosecant of 3 pi over 4, this is going to be equal to 1 over the sine of pi over 4, which is going to be the square root of 2 over 2 being flipped. So it would be 2 over the square root of 2. And of course, if you simplify that, you could basically say this is the square root of 2. Let me move over a little bit. Times the square root of 2. This would cancel, and you get the square root of 2. So whether I'm working with the cosecant of pi over 4 or the cosecant of 3 pi over 4, I'm in quadrant 1 or 2, so cosecant or sine are both positive. That's going to give me the square root of 2. So then if I go into quadrants 3 and 4, where this guy is negative, so the cosecant of 5 pi over 4, or the cosecant of 7 pi over 4, this is going to be the negative of the square root of 2. Now, when we think about cotangent, this is going to be positive in quadrants 1 and 3. So let me put a little border here for cotangent. So the cotangent of pi over 4, and then also the cotangent of 5 pi over 4, would be equal to positive 1, whereas the cotangent of 3 pi over 4, or the cotangent of 7 pi over 4, so this is quadrant 2 and quadrant 4, that's going to be negative 1. Okay, so now that we have all this information, let's just go through and plug things in. So you want to start with cosecant of pi over 4, so pi over 4, is equal to the square root of 2 times the cotangent of pi over 4. Well, we know the cosecant of pi over 4 is square root of 2. So this right here is square root of 2. And we know the cotangent of pi over 4 is going to be 1. So this is square root of 2 equals square root of 2. So that checks out. So pi over 4 is a valid solution. Now, with the next guy, you're going to have the cosecant of 3 pi over 4. So the cosecant of 3 pi over 4 is square root of 2. So let's just go ahead and write that in. And then for the other side, you have square root of 2 times the cotangent of 3 pi over 4. Cotangent of 3 pi over 4 is going to be -1. So if I multiply this by -1, this would be the negative square root of 2. So those two sides are not equal, so you're going to reject that solution. Okay, let's look at the next one, which would be 5 pi over 4. So the cosecant of 5 pi over 4 is going to be negative square root of 2. The cotangent of 5 pi over 4 is 1, so this would just be square root of 2, so those two are not equal. All right, the next one is 7 pi over 4. So the cosecant of 7 pi over 4 is going to be negative square root of 2, and then the cotangent of 7 pi over 4 is -1, so this is -1 times square root of 2, so negative square root of 2. So those two are equal, so let's go ahead and put a check mark there. So the only valid solutions here would be theta is equal to pi over 4, and then also 7 pi over 4, given the fact that we're in that interval where theta is greater than or equal to 0 and less than 2 pi. So let me go ahead and grab that real quick, come back up here, and so we want to say that it's going to be pi over 4 and then 7 pi over 4. All right, let's take a look at the quiz. For the first question, we're asked to solve over the interval from 0 to 2 pi, where 0 is included and 2 pi is excluded. So we have the absolute value of the tangent of x over 2, and this is equal to the square root of 3. So let me grab this real quick, and let's come down here. I'm just going to make a little substitution, even though it's not necessary. I'm going to let u be equal to x over 2. So for right now, I'm going to erase this x over 2, and I'm just going to plug in a u there. And basically, we'll put this in terms of x at the end. But for right now, we're going to work with it in this form. So the absolute value of tangent of u is equal to the square root of 3. So how do we solve that? Remember earlier in the course, we talked about how to solve absolute value equations. We can just use something simple here. Let's just say we had the absolute value of x, and this equals something like 3. Well, we know that this leads to x is equal to 3, or x is equal to -3. In other words, if I plugged in a 3 for x, the absolute value of 3 is 3. So you get 3 equals 3, that's a true statement. But also if I plugged in a -3 for x, well, the absolute value of -3 is also going to give me +3. So once again, you get 3 equals 3, which is a true statement. So we're going to do the same thing here. We're going to take what's inside the absolute value bars, which is the tangent of u. So the tangent of u, and we're first going to set it equal to the square root of 3. And then we're going to say or. We're going to take what's inside the absolute value bars, so the tangent of u, and now we're going to set it equal to the negative of the square root of 3. So this is what we need to do. Let me go ahead and grab this, and let's come down to the unit circle. You don't need the unit circle, but it's helpful to visualize the solutions. Now, when I think about something like the tangent of u, how often would the solutions repeat? Remember, this is not in terms of x right now. This is in terms of u. So just think about having something like the tangent of x. Just pretend like you had that. How often would your solutions repeat? Well, every pi. We know the standard period for tangent is just pi. So for these solutions, if I ask for the tangent of u equals square root of 3, most of you already know that you're going to have a solution at pi over 3, and then you're also going to have a solution in quadrant 3, where tangent is also positive. That's going to be 4 pi over 3. So in other words, I find this solution, and the period is pi, so I could just swing by another pi to get to my next solution. Now, how did I get that pi over 3? Again, if you're not familiar with this, you could just use your inverse tangent function on your calculator, and then plug in the square root of 3 as the argument, and that's going to give you pi over 3 if you're working with radians, or 60 degrees if you have it set to degree mode. So once you have that first solution, again, you can find additional solutions by adding pi. So in terms of u, let's just put one solution as pi over 3, and then plus pi n, where n is any integer. Now that's for this guy right here. Now what about this other guy here? The tangent of u equals the negative of the square root of 3. Well, coming into quadrant 2, where tangent is negative, I know that I'm looking for an angle with a reference angle of pi over 3. So that's going to be 2 pi over 3. And then basically, like we did before, you can add pi, which is your standard period, and that's going to put you at 5 pi over 3, and that's another solution. And then you can just keep adding pi to get to other solutions. So let's just say that this is 2 pi over 3. Let me make that 3 a little bit better there. And then plus pi n, where n is any integer. Okay, so let's come back up here and we'll put our solution together. So we remember that we let u be equal to x over 2. So now what I'm going to do is just put this as x over 2. And how do we get x? Well, we just multiply both sides by 2. So I'm going to say that x is equal to, everything here needs to be multiplied by 2. So it would be 2 times pi over 3, that's just 2 pi over 3. And then plus 2 times pi n, that's 2 pi n. And then I'm going to go 2 pi over 3 times 2, that's 4 pi over 3. And then plus, again, this would be 2 pi n. So everything got multiplied by 2. Now, in terms of our solution for the quiz, let's go back up. Right now, what we have is the general solution. So if you ask me for the general solution, this is what I would give you. But if you're looking for the solution where x is greater than or equal to 0 and less than 2 pi, what you would do is you would plug in a 0 for n here and then also here. And so if you plug in a 0 for n there, you're just going to get 2 pi over 3. So let me put x is equal to 2 pi over 3. And then if you plug in a 0 for n there, you're going to get 4 pi over 3. So those are our two solutions in this given interval. And then this is the general solution just in case you want it. So let's come down here and select that we want 2 pi over 3 and then 4 pi over 3. Okay, let's take a look at question 2 now. So we're asked to solve over the interval from 0 to 2 pi, where 0 is included and 2 pi is excluded. And we are given the sine of theta is equal to the square root of 3 times your cosine of theta over 2. Okay, let me grab this and let's come down here and paste this in. So you see I have a little half angle identity already ready for us. You can solve this problem using different strategies. If you watch the practice test, you saw that I prefer using a substitution technique and a double angle identity. And the reason I like that is because with this identity here, you're going to have to square both sides to get rid of this square root guy. And so that introduces the possibility of extraneous solutions or solutions that do not work in the original equation. So that gives you the added time of checking things. And so if you want to do this more quickly, in the next problem, if you haven't seen the practice test, I'll go over the substitution technique, and that's something that I feel is a little bit faster. So let's do this using this strategy here. And the first thing I would actually do is square both sides of the equation. So I'm going to say this is sine squared theta. So I'm just squaring this right here is equal to, I'm going to square this like this so nobody's lost. So the square root of 3 times the cosine of theta over 2 being squared. And so let me tighten this in. So this would actually be the square root of 3 being squared like this. And then this would be the cosine of theta over 2 being squared like this. So this is basically multiplication. So square root of 3 being squared is going to just be 3. So this is very straightforward. Cosine of theta over 2 being squared, normally you would write that as cosine squared theta over 2, but I'm doing this because we're going to plug in. So in other words, we have cosine of theta over 2 right here, and then we have cosine of theta over 2 right here. So I'm going to take this part right here, so this part right here, and just plug it in right here. So I'm going to write that I have sine squared theta is equal to 3 times, in the parentheses, I'm going to plug this in, so plus or minus the square root of 1 plus the cosine of theta. This is over 2. Let me make that a little bit better. And then let me close this down and say this is squared. Okay, on the left, I'm just going to copy sine squared theta. And this equals, I'm going to put 3. And then let me actually put some parentheses here, because this 3 needs to be multiplied by whatever the result of this is. So this right here is being squared. So the plus or minus is going to go away. Okay, so if you square a plus or minus, the positive being squared is still going to be positive. A negative being squared is going to be a positive. So get rid of this. The square root being squared, those are going to cancel. So you just have the radicand here. That's 1 plus the cosine of theta, and this is over 2. So the reason I have the parentheses here is because the 3 needs to multiply by this whole thing. Okay, so you could do it like this. So just go ahead and put the 3 out in front. So we would have sine squared theta is equal to, this 3 is going to get distributed to each guy. So let's say 3 plus 3 cosine of theta, and then this is over 2. Now at this point you have sine squared theta, and over here you have 3 cosine of theta. So what can we do? Remember that you have this identity, which is cosine squared theta plus sine squared theta is equal to 1. So all you have to do is basically subtract cosine squared theta away from each side. So I'm going to go minus cosine squared theta. And then basically this right here matches this right here. So I can plug this guy right here in for this guy right there. So the left side is going to turn into 1 minus cosine squared theta, and this equals 3 plus 3 cosine of theta over 2. So now I have this cosine squared theta and this cosine of theta, so I'll be able to get this in terms of cosine of theta equals some number. That's what I want. So now if I look, I have this denominator of 2, so let's get rid of that. I'm going to multiply both sides by 2. Make sure you wrap this. So this 2 would cancel with this 2, and then over here, this 2 needs to be distributed to each guy inside the parentheses. So you're going to get 2 minus 2 cosine squared theta, and this equals, I'm going to leave a little space here, we have 3 plus 3 cosine of theta. So I'm going to subtract 3 cosine of theta away from each side. Let me slide this down so this fits. I'm actually just going to do this up here. So minus 3 cosine of theta. And so this is going to cancel, and then I'm going to subtract 3 away from each side of the equation. So this right here is going to cancel. So the right side is 0. Now the reason I'm doing that is because if I have a squared guy involved, I'm thinking this is quadratic in form, and I want to, in most cases, solve it with factoring in the zero products property. You can't always do that, but in a lot of cases you can. So I'm going to write this as negative 2 cosine squared theta, and then minus 3 cosine of theta. And then over here, 2 minus 3 is negative 1. So this is minus 1 equals 0. Okay, just come to a fresh sheet here so we don't run out of room. What I would do, I'm going to try to factor the left side. To make that easier, I'm going to multiply everything by negative 1. So that's just going to change the sign of everything. So this would become positive, positive, positive. And of course, there's no change to 0. 0 times anything is 0. So then what I would do is factor this guy. And it's pretty easy to factor. 2 is a prime number. So I can say this is 2 cosine of theta. And then cosine of theta. Of course, 2 cosine of theta times cosine of theta is 2 cosine squared theta. And then this plus 1 here at the end is coming from this times this. So 1 only comes from 1 times 1 or negative 1 times negative 1. This guy in the middle is a positive. So I know this is a positive 1 and a positive 1. So if you check, this is 2 cosine of theta, and then this is cosine of theta. And if you add those 2 cosine of theta plus cosine of theta, well, that's 3 cosine of theta. That's what you want in the middle. Okay, so now that we have factored this guy, we're going to use the zero products property. So take each factor here, set it equal to 0, and solve. So we're going to say 2 cosine of theta plus 1 is equal to 0. And then or we're going to have cosine of theta plus 1 is equal to 0. Okay, let me slide this out of the way. I'm just going to clean this one up first. So I would subtract 1 away from each side. Let me just erase it and say this equals negative 1. And then divide both sides by 2. And so you get cosine of theta equals negative 1/2. Down here, you could just subtract 1 away from each side. So cosine of theta equals negative 1. Now, you don't really have to think about the general solution for this one. It's a little bit more involved if you want to do that. So right now, the interval that we're working with, we're told that theta is going to be greater than or equal to 0 and less than 2 pi. We didn't use any sort of substitution here. So basically, all we need to do is find the values that work for theta from here and here, and then check them, and we only need to go in this interval. That's all we have to do. So we want the cosine of theta equaling to negative 1/2. So that is going to be a pi over 3 reference angle in quadrants 2 and 3. So in quadrant 2, that's going to be 2 pi over 3. You see that negative 1/2 for the x-coordinate. And then in quadrant 3, that's going to be here. You see that negative 1/2 for the x-coordinate. That's at 4 pi over 3. Then cosine of theta equals negative 1. That's going to be right here at pi. So you see that's negative 1 there for the x-coordinate. If you wanted to find the general solution, and I'm not going to do that here, you would need to extend this out to 4 pi. So basically what you'd have to do is add another 2 pi to this, add another 2 pi to this, and add another 2 pi to this. So that would give you 6 total solutions that you'd have to check. Right now, it's just going to be 3, and I'm just going to keep it simple. So I'm going to say that theta is equal to 2 pi over 3, and then we have pi, and then we have 4 pi over 3. So these are proposed solutions. We squared both sides of our equation, so we have to check and verify that they work. Okay, let me copy this, and let me come back up here and paste this in. So this is the part that I don't like, and it's just time consuming to go back and check and see what works and what doesn't. So we're going to actually find that all 3 of these work, but we have to check them. So sine of 2 pi over 3, and then is this equal to the square root of 3 times the cosine of, you would have 2 pi over 3, basically times 1/2. So the 2's there are going to cancel. So you would have the cosine of pi over 3. We know that's 1/2. And then 1/2 times square root of 3 is square root of 3 over 2. Now the sine of 2 pi over 3, you have a pi over 3 reference angle in quadrant 2 where sine is positive. So this is also square root of 3 over 2. So this is square root of 3 over 2 equals square root of 3 over 2. So this works. The next one is pi. So you have the sine of pi, which is 0, is equal to the square root of 3 times the cosine of, you're plugging in a pi there, so you're going to have a pi over 2, and cosine of pi over 2 is 0. So basically you have the square root of 3 times 0, which is going to be 0. So you get 0 equals 0, so this is a true statement. Now the last guy is 4 pi over 3. You're going to see this works as well. So sine of 4 pi over 3, you're in quadrant 3 now, so sine is negative, and you have a pi over 3 reference angle. So this is going to be negative square root of 3 over 2. And then is this equal to the square root of 3 times the cosine of, you're going to have 4 pi over 3 times 1/2. So this right here, this 4, we cancel with this 2. And give me a 2 up here. So this is cosine of 2 pi over 3. Now 2 pi over 3 is in quadrant 2. Cosine is negative there. And you have a pi over 3 reference angle. So basically this would be negative 1/2. And if you multiply square root of 3 times negative 1/2, you're going to get negative square root of 3 over 2. So this is a valid solution as well. So these are our solutions in that interval. Again, if you wanted to get the general solution, because of the way this is set up, the period of this right here is 2 pi, and then the period of cosine of theta over 2, that's going to be 4 pi. So you'd have to think about the least common multiple of those guys, and it's going to be 4 pi. So what you'd have to do is check all the solutions where theta is greater than or equal to 0 and less than 4 pi. So in other words, we were looking at cosine of theta is equal to negative 1/2, and then or cosine of theta equals negative 1. So you have to go out to this 4 pi guy. 4 pi is not included, but I think you understand what I'm saying there. You would have to collect those solutions and then check them. Then any valid solution, you'd want to put plus 4 pi n, where n is any integer. But again, we're not doing that here, so I'm not going to go through it. So basically, I'm just going to put this as the solution. So we're looking for this guy right here. So theta is 2 pi over 3, then pi, and then 4 pi over 3. Okay, let's take a look at question 3. So we're asked to solve over the interval from 0 to 2 pi, where 0 is included and 2 pi is excluded. And we have 4 cosine of theta over 2 is equal to negative 3 minus the cosine of theta. So for this one, let me write it out. So 4 cosine of theta over 2 is equal to negative 3 minus the cosine of theta. Let me grab this real quick, and let me come down here. So you see I have a little cosine of 2u equals 2 cosine squared u minus 1. So this is my double angle identity for cosine, or at least one of them. There's 3 different forms. And I'm going to use that along with a little substitution technique. And I'm going to show you that these problems are a little bit faster if you do this. Now, one thing I would consider here before I even start, in the last example, I just solved over the interval we needed to solve over, and it was really not an issue. With this one, I would really think it's better to work in terms of the general solution and then just plug in to get what fits in the interval. Now, to work in terms of the general solution, you need to know how often solutions repeat. When you look at the period for this guy right here, just the cosine of theta over 2, that's going to be 4 pi. And when you look at the period for this, it's going to be 2 pi. It's just standard cosine of theta is 2 pi for the period. So you want the least common multiple of the periods, and that's going to be 4 pi. So when we get a general solution, we would expect it to say plus 4 pi n, where n is any integer. So when we think about the substitution, let me put let u be equal to theta over 2, and then I'm going to say that we can multiply both sides by 2, so this is 2u is equal to theta. Okay, so here I'm going to have 4 cosine of, for theta over 2, I'm going to plug in a u, and this equals negative 3, and then minus the cosine of, for theta, I'm going to plug in a 2u. In terms of this guy right here, now if you have just the cosine of u, the period is 2 pi, and then the cosine of 2u, the period there is only pi. So the LCM, or the least common multiple, is 2 pi now. So when I solve this guy right here, I expect the solutions to repeat every 2 pi. So that's really important, and you need to remember that for later on. So let me get rid of this for right now. We don't need it anymore. We just need to remember that we let u be equal to theta over 2, and we're good to go. So bring this up here, and basically, you would notice that cosine of 2u here matches cosine of 2u here. So all you have to do is take this guy right here, and you're going to plug it in for this guy right here. Be very careful about that minus sign right there. That'll cause a lot of trouble for students. So you have 4 cosine of u is equal to negative 3, and then minus, I'm plugging this in, so let me wrap this with parentheses, 2 cosine squared u minus 1, close that down. So this minus needs to basically be distributed to each guy. Again, you can always go plus negative 1 and show it like this if that's more convenient for you. So this needs to go all the way over there. So we have 4 cosine of u is equal to negative 3. And then negative 1 times 2 cosine squared u is negative 2 cosine squared u. And then negative 1 times negative 1 is positive 1. So at this point, if I have a squared guy, I'm thinking this is quadratic in form, and I can go ahead and solve it using factoring. It's not always going to work out that way, but usually that's the case. So I'm going to push all my terms to one side and have the other side be 0. So I'm going to first say -3 plus 1 is -2. Let me write this back here as -2. And let me slide this over here so I have a little bit of room. And I'm going to add 2 cosine squared u to both sides. Can I fit that? I think probably not. Let me slide that over. So 2 cosine squared u, like that. And so this is going to cancel. And I'm also going to add 2 to both sides. I don't think I can fit that, so let me just write it like that. That's going to cancel. So the right side is 0. On the left, I'm just going to say this is 2 cosine squared u, and then plus 4 cosine of u, and then plus 2. And of course, this equals 0. Now, one thing you would notice is that you have a 2, you have a 4, and then you have a 2, and you have a 0. I can divide everything here by 2 and make it easier to work with. So divide this by 2, this by 2, this by 2, and this by 2. 2 divided by 2 is 1. So this is cosine squared u, and then plus 4 divided by 2 is 2. So this is 2 cosine of u, and then plus 2 over 2 is 1, and this equals 0. All right, so this guy can be factored into a quantity squared. But to show you that, let me just set this up as we usually would. This is cosine squared u. So this is just cosine of u times cosine of u. So cosine of u times cosine of u is cosine squared u. And then this right here is plus 1. Well, that can only come from 1 times 1 or -1 times -1. Well, this is a plus right here, so this has to be a plus 1 and a plus 1. And that works, right? The outer is cosine of u. The inner is cosine of u. If you add those together, you get 2 cosine of u. And of course, 1 times 1 is 1. So this becomes cosine of u plus 1, quantity squared, and this equals 0. So very easy to solve this. You would just take what's inside, so the cosine of u plus 1, and I'm going to just set that equal to 0. I'm going to solve this equation, so subtract 1 away from each side. This cancels, and you get the cosine of u is equal to -1. Okay, let's come down here, and I have the cosine of u is equal to -1. So that is only going to happen here at pi. So that's where you have a -1 for the x-coordinate. Now remember, I told you that in terms of u, solutions repeat every 2 pi. Okay, so every 2 pi. So you would write that u is equal to pi, let me make this a little bit better, and then plus 2 pi n, where n is any integer. Remember that initially we said that theta over 2 was equal to u. So let's say u is equal to theta over 2. So all I have to do here is plug in theta over 2. And then if I want theta, I would multiply everything by 2. So we would say theta is equal to, this would be 2 pi plus 4 pi n, just multiplying this by 2 and this by 2. Okay, well, thinking about this in terms of the interval we're given, we are given theta is greater than or equal to 0 and less than 2 pi. Am I going to have a solution in this interval? No, because if I plugged in a 0 here for n, well, what's going to happen is you're going to have theta is equal to 2 pi, and that is not in this interval because 2 pi is excluded. So basically, you're going to say that in this interval, there's not going to be a solution. There is a solution. Let me bring that back. This right here is called the general solution. So there are solutions, but just not in this interval. So we would say there's no solution in this interval that we were given. All right, let's take a look at question 4 now. So we want to solve over the interval from 0 to 2 pi, where 0 is included and 2 pi is excluded. And we have 2 times the sine of, you're going to have this x over 2 plus this pi over 4. And then this equals the square root of 2, and then times your cosine of x over 2, and then plus 1. Okay, so here's how I'm going to solve this particular problem. I'm going to use this sum identity for sine that we learned a long time ago. So basically 2 is multiplying this. You could wrap this with some brackets if you want to make that crystal clear. So you could put 2 times, let me put these brackets here. You're going to use this formula here. So it's going to be the sine of the first guy, x over 2, and then times the cosine of the last guy, so pi over 4. And then you're going to have plus, it's the cosine of the first guy. So cosine of x over 2, and then times the sine of the last guy, so pi over 4. Let me close that down. This equals the square root of 2, and then times your cosine of x over 2, and then plus 1. Okay, we know that the cosine of pi over 4 and the sine of pi over 4 is square root of 2 over 2. So let me say that this is 2. I'm just going to distribute this in as I do this. So 2 times the sine, or actually let me put this one out in front. So 2 times the square root of 2 over 2, and then times your sine of x over 2, and then plus, let me put this one out in front, so 2 times the square root of 2 over 2 times the cosine of x over 2, and this equals the square root of 2 times the cosine of x over 2, and then plus 1. Okay, when you look at this, the 2 here would cancel with the 2 here, the 2 here would cancel with the 2 here, so you have the square root of 2 sine of x over 2, and then plus the square root of 2 cosine of x over 2, and this equals, you have the square root of 2 cosine of x over 2, and then plus 1. So I'm going to subtract the square root of 2 cosine of x over 2 away from each side of the equation. So this will cancel and this will cancel. You have the square root of 2 sine of x over 2, and this is going to be equal to 1. Now, before I do anything, again, when you think about the sine of x over 2, you think about the period of that being 4 pi. So solutions will repeat every 4 pi. Now, what I'm going to do to make this a little bit easier to understand, I'm just going to make a substitution. So I'm going to say we're going to let u be equal to x over 2. Again, you don't have to do that, but I find it to be a little bit easier, especially if you're just starting out. So now when I think about the sine of u, that's the regular period of 2 pi. So any solution we find will repeat every 2 pi. Okay, so let's grab this real quick and just come down to a new sheet. What I would do is divide both sides by the square root of 2. And basically this would cancel. So you'd have the sine of u is equal to 1 over the square root of 2. Of course, you can rationalize the denominator. Some people won't in this situation, but it's up to you. So this would be the square root of 2 over 2. So where do we have a sine value of square root of 2 over 2? Well, it's going to be right here at pi over 4. So that's in quadrant 1. And then also sine is positive in quadrant 2. So that's going to be at 3 pi over 4. Again, in quadrant 2, you have a pi over 4 reference angle, another way to think about it. So let's write u is equal to pi over 4. And then plus, again, solutions in terms of u repeat every 2 pi. So I'm going to write 2 pi n, where n is any integer. And then I'm going to write 3 pi over 4 plus 2 pi n, where n is any integer. So remember that we said that u was equal to x over 2. Again, all you have to do is plug this back in. I think it makes it a lot easier. And we would expect solutions now to repeat every 4 pi, and you're going to see that they do. You're going to multiply everything by 2. So let's say x is equal to, if you multiply 2 times pi over 4, this is going to cancel with this and give you a 2 down there, so that's pi over 2. So this is pi over 2, and then plus, you'd multiply this by 2, so you can have 4 pi n, and then 3 pi over 4, so 3 pi over 4, and then times 2. This 2 cancels with this 4 and gives me a 2, so this is 3 pi over 2. And then plus, multiply this by 2, you get 4 pi n. So that's your general solution in case you want it, but we only want where x is greater than or equal to 0 and less than 2 pi. So plug in a 0 here and plug in a 0 here. That's going to give you pi over 2 and 3 pi over 2. So those are the solutions we're looking for. So let me put x is equal to pi over 2 and then 3 pi over 2. So that's what we're looking for. So that's going to be right here. Again, pi over 2 and 3 pi over 2. All right, let's take a look at question 5. So we're asked to solve over the interval from 0 to 2 pi, where 0 is included and 2 pi is excluded. And we have the secant of x over 2 minus 4 cosine of x over 2, and this equals 0. Now I'm going to do a few things. There's a lot of different methods you could use to solve this. I think the most straightforward is just to use the substitution. So I'm going to let u be equal to x over 2. Again, you don't have to do this. I just find it to be helpful, especially if you're struggling. So when I look at this guy right here, I know that the solutions would repeat every 2 pi. Secant of u, if I think about the period of that, it's 2 pi. Cosine of u, the period of that is 2 pi. So when I get solutions, they repeat every 2 pi. Now that we know that, let's think about what it means to have the secant of u. We know that the secant of u is equal to, by definition, 1 over the cosine of u. So I'm just going to replace this with 1 over the cosine of u. Let me get rid of this. I think we know that at this point. And then we have minus 4 cosine of u, and then this equals 0. So how do we solve this? What I would do is get a common denominator. So let me erase this right here and scooch this down like this. So let me put this over 1. I'm going to multiply by the cosine of u over the cosine of u. And so this gives me 1 over the cosine of u minus 4 cosine squared u over the cosine of u, and this equals 0. we have a common denominator. So I can just say this is 1 minus 4 cosine squared u. And then this is over your cosine of u, and this equals 0. Now, if I'm trying to solve this, the way I would do it is I would think about what can I not do down here? I don't want division by 0. So in other words, I would set cosine of u equal to 0, and I would solve that. You can come to the unit circle. Again, think about where cosine is 0. So right there at pi over 2 and right there at 3 pi over 2. So basically, in terms of u, that solution, if you said cosine of u is equal to 0, it would be pi over 2 plus 2 pi n, where n is any integer. And you'd have 3 pi over 2 plus 2 pi n, where n is any integer. But you could combine those because it's happening every pi. So you would just say pi over 2 plus pi n, where n is any integer. Let's bring this back up. So I'm just going to put that the domain for this right here is going to be the set of all u such that u is not equal to, you have pi over 2 plus pi n, where n is any integer. So all I have to do now is just set the numerator equal to 0 and solve that. So as long as the numerator is 0 and the denominator is not 0, we will solve this equation because you'd have 0 over something not 0. That, of course, would give you 0. So let's say that we have 1 minus 4 cosine squared u is equal to 0. Lots of ways to solve this. I'm just going to subtract 1 away from each side. Cancel this. I have negative 4 cosine squared u is equal to negative 1. And so here I would divide both sides by negative 4. So this would cancel, and you're going to get cosine squared u is equal to 1/4. So let me come down here. So we have cosine squared u is equal to 1/4. So by the square root property, you can say the cosine of u is equal to plus or minus the square root of 1/4. Now, what's the square root of 1/4? That's going to be 1/2. So cosine of u equals, let's just put this as 1/2, and then or, that one could be better. We'll say or cosine of u is equal to, let's say, negative 1/2. Okay, so let's say u is equal to what? Where is cosine of u equal to 1/2? Well, I'm looking for an x-coordinate of 1/2. That's going to be right there at pi over 3, and then also right here at 5 pi over 3. And then where is cosine of u equal to negative 1/2? Well, that's going to be right here. There's your negative 1/2. That's at 2 pi over 3. And then right here, that's going to be at 4 pi over 3. Let's write those solutions in. Remember, this is in terms of u. So we have pi over 3. And let me slide this down a little bit. I'm going to put plus 2 pi n, where n is any integer. Then I'm going to put 2 pi over 3 plus 2 pi n, where n is any integer. Let me get rid of this. This is not going to fit. And then I'm going to put 4 pi over 3 plus 2 pi n, where n is any integer. And then I'm going to put 5 pi over 3 plus 2 pi n, where n is any integer. So when you look at these, this solution here and this solution here, those can be combined. So pi over 3, I can just say plus pi n. So get rid of this one right here. And then this solution right here and this solution right here can be combined. So it's 2 pi over 3 plus pi n. So get rid of this. So that's a lot more concise. So these would work in terms of u. And I'm just going to come back here and replace this again with x over 2. Multiply everything by 2. You're going to have x is equal to 2 pi over 3. That's just 2 times pi over 3. And then plus, you'd have 2 pi n. That's just 2 times pi n. And then you'd have 2 times 2 pi over 3. That's 4 pi over 3. Plus 2 times pi n is 2 pi n. Now, if you're thinking, well, why are the solutions not repeating every 4 pi? Remember, we combined solutions. So that's why we have these. If you wanted to go back to those longer solutions and write those all out, you can do that, but this is just more concise. So this right here would be your general solution. And essentially, if you want to look for the interval where x is greater than or equal to 0 and less than 2 pi, well, you'd plug in a 0 here and here. So plug in a 0 for each n, and you'd have 2 pi over 3 and 4 pi over 3. So those are your solutions. So x would be equal to 2 pi over 3 and then 4 pi over 3. So looking for that, I'm going to have this right here. So 2 pi over 3 and then 4 pi over 3. All right, let's take a look at the quiz. For the first question, we're asked to solve over the interval from 0 to 2 pi, where 0 is included and 2 pi is excluded. And we have 2 sine of 2 theta is equal to the sine of 2 theta plus the square root of 2 sine of theta. Okay, so we're going to use a little identity, and we're going to replace the sine of 2 theta with this guy right here. But before we do that, let's make this a little bit simpler. Let's subtract the sine of 2 theta away from each side of the equation. So this right here is going to cancel away. And I'm going to have 2 sine of 2 theta minus the sine of 2 theta, which is going to be the sine of 2 theta. And this equals, we're going to have the square root of 2 sine of theta. You have the sine of 2 theta right here, and you have the sine of 2 theta right here. So all we're going to do is we're going to take this right here, and we're going to plug in for this right here. So we're going to have 2 sine of theta cosine of theta is equal to the square root of 2 sine of theta. All right, so now what I would do is move this over to the left so I could factor. So I'm just going to subtract the square root of 2 sine of theta away from each side of the equation. I don't know if I can actually fit that in there. So let me put that in like that. And then this would cancel and give me 0. So on the left, you have 2 sine of theta cosine of theta minus the square root of 2 sine of theta, and this equals 0. So you're going to be able to factor out the sine of theta. So you have sine of theta and sine of theta. So basically, we're going to pull that out in front of some parentheses. So we're going to have the sine of theta times the quantity. You would have 2 cosine of theta, then minus, this would just be the square root of 2, and then this equals 0. Okay, so using the zero product property, we're going to get that the sine of theta is equal to 0, then or 2 cosine of theta minus the square root of 2 is equal to 0. So for this one, if you add the square root of 2 to both sides, you would get 2 cosine of theta is equal to the square root of 2. And then for this one, if we divide both sides by 2, this would cancel, and you get the cosine of theta is equal to the square root of 2 over 2. So basically, you have sine of theta equals 0. So where's that going to happen? That's going to happen right here at 0, and then right here at pi. Then you have cosine of theta equals square root of 2 over 2. So that's going to be right here at pi over 4. And then cosine is also positive in quadrant 4. So you're looking at quadrant 4, and you want a pi over 4 reference angle. So that's 7 pi over 4. Again, you can just get the x-coordinate of square root of 2 over 2 if you want to do it that way. So again, I'm just working in the interval where theta is greater than or equal to 0 and less than 2 pi. So I can just collect these solutions. So I'm just going to say that theta is equal to 0, and then you would have pi over 4, and then you would have pi, and then you would have 7 pi over 4. So again, we're not asked for the general solution here, so we're not going to give it. So let's go ahead and just grab this, come back up here, and I'm looking for this guy right here. So we want 0, pi over 4, pi, and 7 pi over 4 in this interval. All right, let's take a look at question 2. So we want to solve over the interval from 0 to 2 pi, where 0 is included and 2 pi is excluded. We have 3 sine of theta plus cosine of 2 theta is equal to negative 4 sine squared theta. And I'm just going to slide this over real quick. Didn't mean to grab that. So this is my cosine of 2 theta here. You're just going to say that this right here matches this right here. And so you can, of course, just take this and plug it in right there. That's all you're going to do. So let's say that we have 3 sine of theta, and then plus, just plug this in, 1 minus 2 sine squared theta, and this equals negative 4 sine squared theta. So let me add 4 sine squared theta to both sides of the equation. This is going to cancel and give me a 0. So over here on the left, I'm going to have 4 sine squared theta minus 2 sine squared theta. That's 2 sine squared theta. Then we're going to have plus 3 sine of theta, and then plus 1, and this equals 0. Okay, on the left, can I factor this? So let's see if we can set up some parentheses here. So 2 sine squared theta, that's going to be 2 sine of theta, and then sine of theta. So 2 is a prime number. That's real easy. 2 sine of theta times sine of theta is 2 sine squared theta. This plus 1 here can only come from negative 1 times negative 1 or positive 1 times positive 1. And of course, because this middle guy here is positive, I know this is a plus 1 and a plus 1. That's the only possible way this can be set up. If you check this, this is 2 sine of theta, and this is sine of theta. So that, if you add them together, 2 sine of theta plus sine of theta, that's 3 sine of theta. So this is the correct factorization. All right, so now we want to set each factor equal to 0 and solve. So we're just going to say that we have 2 sine of theta plus 1 is equal to 0. Then or, you're going to have sine of theta plus 1 is equal to 0. So let me move this over here, and let me put a little border here. So for this one, I would subtract 1 away from each side. This would cancel. So you'd have 2 sine of theta is equal to negative 1. And of course, you can divide both sides by 2. So sine of theta would be equal to negative 1/2. For this one, we would subtract 1 away from each side. And so sine of theta would be equal to negative 1. Okay, so looking at things, sine of theta equals negative 1/2. I'm looking for a y-coordinate of negative 1/2. That's going to be right here at 11 pi over 6. And then that's going to be right here at 7 pi over 6. Then sine of theta equals negative 1. That is going to be right here at 3 pi over 2. So again, we're only talking about the solution in terms of theta being greater than or equal to 0 and less than 2 pi. We're not asked for the general solution, so we're not going to give it. So let's just say theta is equal to 7 pi over 6. Maybe that could be a little bit better there. And then 3 pi over 2, so 3 pi over 2. And then we're going to have 11 pi over 6. Okay, so let's paste this in there. So I am looking for this solution right here. So in this interval, it's 7 pi over 6, 3 pi over 2, and then 11 pi over 6. All right, for question 3, again, we're asked to solve over the interval from 0 to 2 pi, where 0 is included and 2 pi is excluded. So we're going to have, let me just write this on the left and this on the right. So 4 sine of theta minus 6 sine squared theta minus the cosine of 2 theta, and this equals 0. So again, you have the cosine of 2 theta and the cosine of 2 theta. So we're just going to take this right here, and I'm going to plug in for this right here. Now be careful about that minus sign there. It's really important. So I'm going to say we have 4 sine of theta minus 6 sine squared theta. And then minus, I'm going to plug this in. Again, I'm using parentheses here so I don't make a sign mistake. So 1 minus 2 sine squared theta. Close that down. Okay, then of course this equals 0. Now, this negative needs to be applied to each guy inside the parentheses. So I'm just going to erase this and this. So this would be negative and this would be positive. So now what I'm going to do is say that I have negative 6 sine squared theta plus 2 sine squared theta. That would be negative 4 sine squared theta. I'm going to write that out in front. So negative 4 sine squared theta. Then I'm going to go plus 4 sine of theta. And then you have negative 1, so minus 1. And let's say this equals 0. Now, because I like to factor, with my leading guy being positive, I'm just going to multiply everything by negative 1. So this would become positive, negative, and then positive, no change to 0. So can we factor this? Yes. So let's go ahead and set this up. And so this 4 sine squared theta, that's only going to come from either 2 sine of theta times 2 sine of theta, or 4 sine of theta times sine of theta. I'm looking at this and I'm thinking this is 2 sine of theta and then minus 1, and then 2 sine of theta and then minus 1. The reason I'm thinking that is that this middle guy here is telling me that I think I have this into a quantity squared. Let's just check it and make sure. So this guy right here would be negative 2 sine of theta, and this would be negative 2 sine of theta. So this would work. Negative 2 sine of theta minus 2 sine of theta, that's negative 4 sine of theta, and negative 1 times negative 1 is positive 1. So you can actually condense this down and say it's 2 sine of theta minus 1 quantity squared, and say this equals 0. Very easy to solve this. You just say 2 sine of theta minus 1 is equal to 0. Add 1 to both sides. And so this would be 2 sine of theta is equal to 1. Divide both sides by 2. This cancels. You get sine of theta is equal to 1/2. Okay, let's grab this. So where is this true? Well, sine is positive in quadrants 1 and 2. So we know that it's pi over 6. Here's the y-coordinate of 1/2. And here it's 5 pi over 6. Here's the y-coordinate of 1/2. Okay, so we would say that for theta being greater than or equal to 0 and less than 2 pi, that theta is equal to pi over 6 and then 5 pi over 6. So let's grab this real quick and let me paste this in. So this is what we want. So in this interval, we have pi over 6 and then 5 pi over 6. All right, let's take a look at question 4 now. So we want to solve over the interval from 0 to 2 pi, where 0 is included and 2 pi is excluded. And what we have here is negative 2 minus 11 sine of 2 theta plus 4 pi over 3. And this equals negative 4 times the square root of 2 minus 3 times the sine of this 2 theta plus 4 pi over 3. Now, there's lots of different strategies you could use to solve this type of problem. What I'm going to do is a little substitution technique. I am going to let u be equal to this 2 theta plus 4 pi over 3. Let me make that 3 a little bit better there. So what I can do is plug in a u here and here, and it's going to make it really easy to solve. So we're going to have negative 2 minus 11, then sine of, now this will be u, is equal to negative 4 times the square root of 2, and then minus 2, and then minus, let me slide this down so it fits, we would have 3, and then sine of, again, for this, it would just be u. So all we have to do at this point is get sine of u equals some number, and then we'll come back and do another substitution, and I'll show you how to solve for theta. For right now, notice you have a negative 2 and a negative 2, so I can add 2 to both sides of the equation, and let's go ahead and just get rid of that. So that's nice and simple. If I want sine of u equals some number, then let's add 3 sine of u to both sides of the equation. So this right here is going to go away. So now what you're going to have on the left is negative 11 sine of u plus 3 sine of u. So that is going to be negative 8 sine of u. And this equals, you're going to have negative 4 times the square root of 2. So I'm going to divide both sides of the equation by negative 8. This is going to cancel. We have the sine of u is equal to negative over negative is positive. If you think about 4 over 8, that's 1/2. So let's write this as the square root of 2 over 2. And we're just going to come to our little unit circle. I know a lot of us know that the solutions here, you're going to have pi over 4. There's your square root of 2 over 2 for the y-coordinate. And then you're going to go into quadrant 2, where sine is also positive. You want a pi over 4 reference angle. So 3 pi over 4. Again, the y-coordinate is square root of 2 over 2. So in terms of u, the solutions would repeat every 2 pi. So I'm just going to put pi over 4 plus 2 pi n. And then down here, let's put 3 pi over 4 plus 2 pi n. Okay, let's come back here and paste this in. So this is the part that gets a little bit tedious. So I'm going to write that u equals this and u equals this. So basically what you're going to do is plug 2 theta plus 4 pi over 3 in for each u. I'm going to do this separately. So let me put 2 theta plus 4 pi over 3 is equal to pi over 4 plus 2 pi n. Let me get rid of this. So this is going to take a lot of room. Let me come down. I'll come back up in a moment. So the first thing is you need to subtract 4 pi over 3 away from each side of the equation. So this would cancel. You get 2 theta is equal to pi over 4, and then basically minus 4 pi over 3. Let me slide this down so I have a little room to get a common denominator. Then you want plus 2 pi n. Okay, so for this, you need a common denominator. So I'd multiply this by 3 over 3 and this by 4 over 4. So this would give me 3 pi minus 16 pi over 12. So this would be 3 pi minus 16 pi over 12. So 3 pi minus 16 pi is negative 13 pi. So this right now would be negative 13 pi over 12. At this point, I want theta by itself. So you have 2 that's multiplying theta. Normally you say you divide both sides by 2, but since we have some fractions involved, let's just multiply by 1/2. I think it's a little bit easier to do it that way. In this particular case, this is going to cancel. So you're going to have theta is equal to, you would have 1/2 times negative 13 pi over 12. That's going to be negative 13 pi over 24. And then plus this 2 pi n times 1/2 is going to end up giving me pi n. Now what I'm going to do is add pi to this. So let's go negative 13 pi over 24. You see you have this plus pi n, so let's just say n was 1. So I'm going to add pi. So I'm just going to add 24 pi over 24. And that's going to give me, that would be 11 pi over 24. So I'm actually going to erase this and just put this like this. So I'm going to put theta equals 11 pi over 24 plus pi n. So I can plug in any integer for n and I'll have a solution. So let me erase the or here and drag this over a little bit. And I'm just going to erase the u and plug in the 2 theta plus 4 pi over 3. Okay, I'm going to get rid of this. And I'm going to actually erase this and move this way down here. So plus 2 pi n. So we know that we need to subtract 4 pi over 3 away from each side. Let me just erase it from over here. And let me move this down here. Again, we need a common denominator. So I'm going to multiply this by 3 over 3. And I'm going to multiply this by 4 over 4. So 3 times 3 is 9. And then 4 times 4 is 16. So this would end up being 9 pi. So this would be 9 pi. And then minus 16 pi. So minus 16 pi over that common denominator of 12. So 9 pi minus 16 pi, that's going to be negative 7 pi. So this is negative 7 pi over 12. So now again, I want theta by itself. So let's go ahead and multiply both sides by 1/2, like this. And essentially, this is going to cancel. And so you're going to have theta is going to be equal to, you have negative 7 pi over 24. So over 24. And then plus 2 pi n times 1/2, that's just going to be pi n. And so essentially what I would do is the same thing I did here. I would take this negative 7 pi over 24 and just add pi, just like I'm plugging in a 1 for n. So that's going to be me adding 24 pi over 24, and that would give me 17 pi over 24. Okay, let me erase this and erase this. And I'm just going to put this in here like this. So I'll just put a little comma and put 17 pi over 24, and then plus pi n. So if you wanted to give the general solution, this is one way you could do it. Now let's go back up and let's look at the answers. Remember, we're looking for theta to be greater than or equal to 0 and less than 2 pi. If you look through your answers, you see that this answer right here has 11 pi over 24, and then it also has 17 pi over 24. So that's the only one that has those two in there. But then you have those additional solutions of 35 pi over 24 and 41 pi over 24. So where's that coming from? Well, essentially, what's going to happen is in this interval, I can add another pi to this one, and I can add another pi to this one. I'd still be in this interval. So I can go 11 pi over 24 plus pi, which is 24 pi over 24, and that would give me the 35 pi over 24. So that's that guy right there. Then for the other one, you'd have your 17 pi over 24 plus your 24 pi over 24. So again, just adding pi. This would give me 41 pi over 24. So that's that solution right there. So in this interval where theta is greater than or equal to 0 and less than 2 pi, you could say theta is equal to 11 pi over 24. You've got your 17 pi over 24, and then you have the 35 pi over 24. Again, that comes from 11 pi over 24 plus pi. And then lastly, you have your 41 pi over 24, and that came from 17 pi over 24 plus pi. So this is the answer that we want. 11 pi over 24, 17 pi over 24, 35 pi over 24, and then 41 pi over 24. So that's going to be for this interval where theta is greater than or equal to 0 and less than 2 pi. Okay, let's take a look at question 5 now. So once again, we want to solve over the interval from 0 to 2 pi, where 0 is included and 2 pi is excluded. So the idea here again, I'm going to make a substitution. You don't have to do it this way, but I find it to be the easiest. So I'm just going to let u be equal to this. So the theta over 3 plus 2 pi over 3. So that's going to be for this and this. So now you can just say that you have negative 8 plus the square root of 2 over 4, and then plus the sine of, again, since u is equal to this, I just say the sine of u. And this equals negative 2 plus 3 halves times the sine of, again, this right here is u, so we'll put the sine of u. So we can grab this and come down here. And what I would do first is multiply everything by 4. That would clear this denominator and this denominator. So let me actually scooch this down so I can fit everything in there. So I'm going to multiply this by 4, and then plus I'm going to multiply this by 4. And then we can manually do this, or actually let me show this so nobody's lost. So multiply this by 4, and then lastly multiply this by 4, and then I have that sine of u. So everything got multiplied by 4. And again, that's just going to clear the denominators. So this would cancel with this. You have negative 8 plus the square root of 2, and then plus 4 sine of u. And this equals negative 2 times 4 is going to be negative 8. And then plus 4 divided by 2 is 2. So 2 times 3 would be 6. So 6 sine of u. All right, so at this point, you see you have negative 8 and negative 8. So you could add 8 to both sides of the equation. That would cancel and that would cancel. And what I would do is subtract the square root of 2 away from each side of the equation. Let me just put this over here like that. and then I'm going to subtract 6 sine of u away from each side of the equation. So that would cancel. So let me slide down here and clean this up. So we would have on the left, this canceled, 4 sine of u minus 6 sine of u, that's negative 2 sine of u. And this equals, over here I have negative square root of 2. Okay, so I'm going to divide both sides by negative 2. And this is going to cancel. So you're going to have the sine of u is equal to negative over negative is positive. So this is the square root of 2 over 2. Now we just did this in the previous problem. We had sine of u equals square root of 2 over 2. We're going to get a different answer because u is equal to something different. But for right now, in terms of u, we know the solutions would repeat every 2 pi. So once again, we're going to go to pi over 4. Again, a y-coordinate of square root of 2 over 2. And we're going to go to 3 pi over 4. Again, y-coordinate of square root of 2 over 2. So let's go ahead and say that u is equal to pi over 4 plus 2 pi n. And then 3 pi over 4 plus 2 pi n. Okay, so let me just put that u is equal to this as well. And I'm just going to put this off to the side. And maybe I'll just write in or like this. And because you need a lot of room for these, let me erase the u and put theta over 3 plus 2 pi over 3. And this equals, I'm just going to copy this. So pi over 4. And then I'm basically going to leave some space here and put this plus 2 pi n all the way down here. And the reason for that is we need to subtract this 2 pi over 3 away from each side of the equation. So we need some room to do that because we do need to get a common denominator. So I'm going to multiply this by 3 over 3, and I'm going to multiply this by 4 over 4. This would cancel. You could just erase it if you want. A little bit cleaner if you do it that way. So this becomes 3 pi minus 8 pi over the common denominator of 12. So this is negative 5 pi over 12. So this right here would be equal to negative 5 pi over 12. So let me erase this and just write this down here as plus 2 pi n. Now, we have theta over 3. If you want theta by itself, you need to multiply everything by 3. So let me multiply this by 3 and slide this down just a little bit. Multiply this by 3 and multiply this by 3. So these 3's would cancel. So you have theta is equal to, if you think about 12 divided by 3, it's going to be 4. So this is negative 5 pi over 4. And then plus 2 pi n times 3 is 6 pi n. Now again, if you think about this solution right here, you could take this and add 6 pi to it. Just think about plugging in a 1 for n. So if you had negative 5 pi over 4 plus, let's do 24 pi over 4, that's going to give you 19 pi over 4. So let me get rid of this and just put this as 19 pi over 4 like that. So let's get rid of that. So that's one answer here for theta. So I'm going to have theta over 3. And let me just say this equals, I'm going to write 3 pi over 4. I'm going to subtract the 2 pi over 3 away now. So basically I'm just subtracting 2 pi over 3 away from each side. I'm just speeding it up. And then plus your 2 pi n. All right, we need a common denominator, so I'm going to multiply this by 4 over 4 and this by 3 over 3. 3 pi times 3 is 9 pi, so this is 9 pi minus 2 pi times 4 is going to be 8 pi, and this is over the common denominator of 12. So 9 pi minus 8 pi is pi, so this is pi over 12. So this right here is going to give me pi over 12. So we have theta over 3. So again, I can just multiply everything by 3 to get theta by itself. So this would cancel. You have theta is equal to 12 divided by 3 is 4. So basically this is pi over 4. And then plus 3 times 2 pi n, that's going to be 6 pi n. Okay, so this is your general solution. Remember that we want theta to be greater than or equal to 0 and less than 2 pi. Now, for this part right here, can you get something in this interval? No. If you think about 19 pi over 4, that is not in this interval. If you put in positive integers here, so let's say you put 1 or 2 or 3 or something like that, you're still not going to be in this interval. If you put in negative integers, you're still not going to be in this interval. So this one is not going to have a solution in this interval. But for this one, if you plugged in a 0 for n, you would get pi over 4. So that's going to be in this interval, but nowhere else. So basically you could say that theta would be pi over 4, and that's it for this interval. So we want this solution right here. All right, let's take a look at the quiz. For the first question, we want to find the exact value. We have the arc cosine of the cosine of negative 20 pi over 3. let's go ahead and say we have the inverse cosine of the cosine of this negative 20 pi over 3. And so basically here, if we think about it, this will only undo this if this angle right here is in the domain of the restricted cosine function. So that's from 0 to pi with both being included. Or you can say from the range of the inverse cosine function, which is also 0 to pi with both being included. So obviously negative 20 pi over 3 is not in that interval. So you'd have to do some additional work here. The first thing is you could figure out what is the cosine of negative 20 pi over 3. And the easiest way to do that is just to find the coterminal angle. So what is the cosine of negative 20 pi over 3? Well, that's going to be equal to the cosine of, again, the coterminal angle here, which is a little bit of work to find. You would say you have negative 20 pi over 3. Now, if you added 2 pi, that wouldn't quite get you there. 4 pi, 6 pi, those wouldn't quite get you there. You would need to actually add 8 pi. So I'm going to add 8 pi, and I'm going to multiply this by 3 over 3 so I can have a common denominator. So this right here would be plus 24 pi over 3. So negative 20 pi plus 24 pi, that would be 4 pi, and that's over 3. So this is 4 pi over 3. Okay, so at this point, we know that the cosine of 4 pi over 3, again, that's a pi over 3 reference angle in quadrant 3, where cosine is negative. So this is going to be negative 1/2. So negative 1/2. Again, if you come to the unit circle, here's your 4 pi over 3, and the cosine value is negative 1/2. Now again, when you think about the inverse cosine function, you're getting something from 0 to pi with both being included. So I cannot give an answer of 4 pi over 3. That would be incorrect. You have to figure out where is the cosine value going to be negative 1/2 in this interval here. So you're looking for this guy right here. And so the angle you want is actually 2 pi over 3. So let's go back, and I'll show you two different ways to do this. Let me erase this. The first thing is you could say that this is equal to the inverse cosine of this right here, the cosine of negative 20 pi over 3. We know that that is negative 1/2. Let me actually go with another step here so nobody's lost. So this is the cosine of 4 pi over 3. And so this is equal to the inverse cosine of negative 1/2. And so this equals, again, 2 pi over 3. So that's the correct answer. The other way you could do this is just to say that, again, I know the angle in quadrant 2 that's going to have the same cosine value as 4 pi over 3 is going to be 2 pi over 3. And that's in the range of the inverse cosine function. So I could really write this as the inverse cosine of the cosine of 2 pi over 3. And now this will undo this, and you just say your answer is 2 pi over 3. So either way, you get the right answer. So let's just select 2 pi over 3. All right, let's take a look at question 2 now. So we want to solve each equation for exact solutions. And we have the arc cosine of x equals the arc sine of 12 over 13. So let me write the inverse cosine of x is equal to the inverse sine of 12 over 13. These problems are very, very easy to solve. Essentially, you just want to take this guy right here, and you want to make a little substitution. So I'm just going to let something like theta be equal to the inverse sine of 12 over 13. So now what you can do is say that you have the inverse cosine of x is equal to, again, if the inverse sine of 12 over 13 is theta, so this just equals theta. So you could take the cosine of each side, or again, you could just use the definition of the inverse cosine function. If the inverse cosine of x equals theta, then that means that the cosine of theta is equal to x. Let me actually just erase this. And actually, I'm going to erase this. We don't really need that information anymore. Here, I'm just going to say that the sine of theta, so the sine of theta is 12 over 13, because again, if the inverse sine of 12 over 13 is theta, well then the sine of theta is 12 over 13. Additionally, we know that theta is in quadrant 1. How do we know that? If you have something positive for the argument for your inverse sine function, you're getting an angle out that's going to be in quadrant 1. Okay, so all we need to do is figure out what is the cosine of theta. So let me make a little border here and say that the cosine of theta is equal to the adjacent over the hypotenuse. Well, right now we know the sine of theta is 12 over 13, and the sine of theta, let me just drag this down here. We know that this is the opposite over the hypotenuse. Let me make this y a little bit better. So I'm just going to rewrite this. And essentially, I can just plug in here that this is going to be 13. I just need to figure out what the adjacent is. Obviously, this is a 5, 12, 13 right triangle. So you can just fill in a 5 right now, or you can do the Pythagorean theorem if you don't realize that. You can also make a sketch. Again, you don't have to, but if you want to, just for completeness, this is your adjacent right here. Again, we'll just call it x, so x is 5. This is your opposite here. We'll call that y, so y is 12. And this is your hypotenuse here. We're going to call that r, so r is equal to 13. In this problem, we don't know the adjacent, so you're solving for that. So you would say x squared plus y squared equals r squared, like we've been doing for all of trigonometry. Again, we don't know what x is, so we do know y is 12. So this would be x squared plus 12 squared is equal to, we know r is 13, so that's 13 squared. Let me make this 3 a little bit better. Now we know that this right here is 144 and this is 169. So you would have x squared is equal to 169 minus 144, which is 25. And basically, because you're in quadrant 1, the x values are positive. So we know that x is the principal square root of 25, which is 5. So again, it's a 5, 12, 13 right triangle. So coming back up, I know that the cosine of theta is 5 over 13. And again, x is equal to the cosine of theta. So let me erase all of this and just say that x here is going to be equal to 5 over 13. So looking through my choices, I want this one right here. If you want to check something like this, all you're basically saying is that the inverse cosine of 5 over 13 equals the inverse sine of 12 over 13. You're basically saying that you're getting the same angle. So in other words, the angle in quadrant 1 with a cosine value of 5 over 13 is the same as this angle over here, again in quadrant 1, with a sine value of 12 over 13. Again, going back to the sketch, so this makes sense, here's your theta. Your cosine value is 5 over 13, and your sine value is 12 over 13. So I know the angle theta is the same. Again, in each case, I'm in quadrant 1. So coming back, that's how you check something like this. So x is 5 over 13. All right, for question 3, we're asked to solve each equation for exact solutions. And we have a lot of hints here, so we know that there's going to be an issue. So we have 6/11 times the arc sine of x over 2. I'm going to write that as the inverse sine of x over 2. And this should be equal to pi. Okay, let's see what happens when we try to solve this. So first, I want to isolate the inverse sine of x over 2. To do that, I'm going to multiply both sides by 11 over 6, like this. So this is going to cancel away and give me a 1. So basically, you have the inverse sine of x over 2 is equal to, this would be 11 pi over 6. Here's where we want to stop, and let me come to the unit circle and just paste this in. So let's think about this for a moment. Where is 11 pi over 6? 11 pi over 6 is going to be right here. So when I think about the inverse sine function, I go from negative pi over 2 to pi over 2, with both being included for the range. Now, when I highlight things there, it looks like 11 pi over 6 is in the range, but it's not. Because again, when you're in quadrant 4, you're rotating clockwise. So if I wanted that guy right there, what I'd have to do is rotate like this, and that would be negative pi over 6. So you're not going to be able to get 11 pi over 6 out from the inverse sine function. It's just not possible. So there's no solution here for x. Now, another thing you could do in this particular case, you could prove it to yourself. If you use your inverse sine definition and say, okay, well, if the inverse sine of x over 2 equals 11 pi over 6, then it must be true that the sine of 11 pi over 6 is equal to x over 2. And 11 pi over 6, if you take the sine of that, you get negative 1/2. So you'd have negative 1/2 is equal to x over 2. If you multiply both sides here by 2, this cancels and this cancels, so you get x equals negative 1. Does that work? We can plug it in right here and see that it doesn't. If you plug in a negative 1 for x there, you'd have the inverse sine of negative 1/2, and that is not 11 pi over 6. Again, when you look at it, it sort of looks like it will be, because when you look at the range for the inverse sine function, if you're not really paying attention, you say, okay, well, I can get 11 pi over 6 out of that, but you can't. Remember, you have to rotate clockwise. So this angle right here is going to be negative pi over 6. So the inverse sine of negative 1/2 is not 11 pi over 6, it's negative pi over 6. So basically you would get negative pi over 6 is equal to 11 pi over 6, and that is absolutely false. So these guys are not equal. So coming back up, you would say there's no solution. All right, let's take a look at question 4. So this one's a bit involved. We have the arcsine of x plus the arcsine of 2x equals pi over 2. So let's write the inverse sine of x, and then I'm going to say this is equal to pi over 2 minus the inverse sine of 2x. So the first thing you'd want to do, or the first thing that I suggest you do, is make a substitution. So I'm going to make a substitution for this right here. So the inverse sine of 2x, you could let something like theta be equal to that. So the inverse sine of 2x. And once you do that, then you can use your definition of the inverse sine function to say that the sine of this angle theta here is going to be equal to, this is your sine value here, it's going to be 2x. All right, so now that you've done that, basically you can go through and make a little replacement in the problem. So the inverse sine of x is equal to pi over 2, and then minus, now you have theta. Right, because again, theta is the inverse sine of 2x. All right, at this point, I'm going to look at the restrictions. So I'm going to say for the first guy here, this inverse sine of x, we know that that gives me something from negative pi over 2 to pi over 2, with both being included. So let me say that negative pi over 2 is less than or equal to this pi over 2 minus theta, which is less than or equal to this pi over 2. Now you have this negative theta here, and that's a bit of an issue. So what I would do is actually just multiply everything by -1. So this would become positive. This sign has to flip. Remember, if you multiply both sides of an inequality by a negative, well, then you have to flip the direction of the inequality symbol. Well, here you have a 3-part inequality, so you're going to have to flip the direction of each inequality symbol. So this becomes negative, this becomes positive, this gets flipped, and this becomes negative. So once you set that up, go ahead and rewrite it in the order of the number line. So you have negative pi over 2, and we're going to say is less than or equal to. You're going to have theta, and then minus pi over 2, and then which is less than or equal to, you're going to have pi over 2. So once you've set that up, you can delete this from here. You don't need it anymore. And now you're going to add pi over 2 to each part. So negative pi over 2 plus pi over 2 is 0. So this would be 0 is less than or equal to. This would go away, so you have your theta. Let me make that a little bit better, which is less than or equal to, you've got to add pi over 2 plus pi over 2. And of course, that's going to give you pi. But again, to do it, pi plus pi is 2 pi. So 2 pi over 2 is just going to be pi. Okay, so right now, we're saying that theta is greater than or equal to 0 and less than or equal to pi. But there's something else that you have to consider. We also said that theta is equal to the inverse sine of 2x. So I know that theta, based on the definition of the inverse sine function, has to be from negative pi over 2 to pi over 2. So I'm going to say and for number 2, theta is greater than or equal to negative pi over 2 and less than or equal to pi over 2. So you want the intersection of these two. So basically it would be, so theta is greater than or equal to, when I look at these two on the left, you want the one that's larger. So 0 is greater than negative pi over 2, so you're going to use 0. It has to work in both, so that's why you're choosing that. And less than or equal to, here you have pi, and here you have pi over 2. You have to choose the one that's smaller here. So pi over 2 is less than pi, so you're going to say pi over 2. Okay, let's get rid of this. And at this point, we know that basically if I'm sketching a triangle, I'm going to do it in quadrant 1 because theta is greater than or equal to 0 and less than or equal to pi over 2. Let me put a little border here, and we'll put this up here. You might want to write that down for your notes if you're trying to solve this with me. Okay, so at this point, we're basically ready to go. You would take the sine of each side, or you can just use the definition of the inverse sine function and say if the inverse sine of x is equal to pi over 2 minus theta, well then the sine of this pi over 2 minus theta is going to be equal to x. So let me write it like that. And I'm just going to grab this real quick, come down here and paste this in. Let me again write that theta is greater than or equal to 0 and less than or equal to pi over 2. So let me use my difference identity for sine here. So x is equal to the sine of the first guy, so that's the sine of pi over 2, and then times the cosine of the second guy, so the cosine of theta. And then you have minus, you have cosine of the first guy, so cosine of pi over 2, and then times the sine of the second guy, so the sine of theta. Well, if we go to the unit circle, here's pi over 2. the cosine value was 0 and the sine value was 1. So for this, we know we're plugging in a 1, and for this, we're plugging in a 0. So this is going to go away. Basically, you're just going to say that x is equal to the cosine of theta. Now, do I know what the cosine of theta is? At this point, I do not. I just know that the sine of theta is 2x, and theta is greater than or equal to 0 and less than or equal to pi over 2. So you can come to a little sketch. So here is the sine of theta, and we're going to say that is 2x over 1. So this is the opposite, and this is the hypotenuse. So this is your opposite here. Again, I've sketched theta in quadrant 1 because we said theta is greater than or equal to 0 and less than or equal to pi over 2. So 2x here is the opposite. And then basically the hypotenuse is 1, so that's right there. And all we need to do is figure out what is the adjacent. So the adjacent here, the adjacent is this guy right here. So this is equal to the square root of 1 minus 4x squared. And I'm just getting that from the Pythagorean theorem. If you want to go through that real quick, we can just say that, okay, you have 2x squared. Remember to wrap that and square it like this. Plus, you would want this guy, which is unknown squared. Normally we use x for that, but again, because you have an x involved here, I don't want to confuse anybody. So I'm literally just going to write adjacent like this, squared. And this equals the hypotenuse is 1, so 1 squared. So all you would do is square this. So this would be 2 squared, which is 4, times x squared, which is 4x squared. So you'd have the adjacent squared is equal to 1 squared is 1. I'm going to subtract that 4x squared away from each side. So minus 4x squared. And then just take the principal square root, because you know that, again, if you're in quadrant 1 here, this adjacent is going to be positive. So we would say that the adjacent here is equal to the principal square root of 1 minus 4x squared. So that's where that's coming from. And at this point, we know that the cosine of theta is equal to, what's the adjacent? The adjacent is the square root of 1 minus 4x squared. What's the hypotenuse? It's 1, so you can put it over 1 if you want, or just leave it. So let's go ahead and grab this, come back, and paste this in. Let me slide down a little bit. So x is equal to the cosine of theta, and the cosine of theta is equal to the square root of 1 minus 4x squared. So let me put that this is equal to the square root of 1 minus 4x squared. And let's see if we can work on this now. So what I would do is square both sides. So you would square this side and then square this side. So you'd have x squared is equal to, so this is going to be undone by this, and you have the radicand, so 1 minus 4x squared. Go ahead and add 4x squared to both sides of the equation. So we're going to see that this is going to cancel away. X squared plus 4x squared is 5x squared, and this equals 1. Divide both sides by 5. Let me move this up here. This is going to cancel. You're going to end up with x squared is equal to 1/5. By the square root property, you get x is equal to plus or minus the square root of 1 over the square root of 5. So for this one, the square root of 1 is 1. So basically plus or minus 1 over the square root of 5. Now you can rationalize the denominator there. You multiply by the square root of 5 over the square root of 5, and you're going to get x is equal to plus or minus the square root of 5 over 5. Now let me get rid of this, and let's think about this. Do we need the negative here? No. If we go back to the sketch, remember, when I'm thinking about my x here, I'm not thinking about this x in terms of the adjacent that we're normally thinking about. I'm thinking about this x right here. So this opposite right here, I know that's going to be non-negative, right? It can't be negative because theta here is greater than or equal to 0 and less than or equal to pi over 2. So this can't be negative. So coming back, I can get rid of this negative solution and just say x equals the square root of 5 over 5. So let me grab this, come back up, and paste this in, and we'll come down here and x equals the square root of 5 over 5. Now, with a calculator, you can check this. This is not something you can get from the unit circle, but you can punch this into your calculator and say the inverse sine of square root of 5 over 5 plus the inverse sine of 2 times the square root of 5 over 5. Is that equal to pi over 2? And the answer is yes. If you key this into your calculator, you're going to get pi over 2 is equal to pi over 2. So this is a valid solution. Now, another way you can look at this, if you're a little bit lost, you can always go to Desmos. I just took our equation and I subtracted pi over 2 away from each side. So of course that would give me a 0 right here. So if you plug in a 0 for y, you were just asking for which x value am I going to get a y value of 0. So you want that x-intercept right there. And basically, if you approximate the square root of 5 over 5, you're going to get about 0.447. So that's consistent with what we found with our problem. All right, let's take a look at question 5 now. So we want to solve each equation for exact solutions. So we're given the arc cosine of x plus the arc sine of 2x equals pi over 6. So I gave you a lot of hints and identities that you can use. It's really up to you what path you want to go down. I'm just going to use the longer approach in case you want to see that. So let me rewrite the problem as the inverse cosine of x and then plus the inverse sine of 2x is equal to pi over 6. And come down here. And again, we're just going to start in the normal way. I'm going to isolate the inverse cosine of x. To do that, I'm going to subtract the inverse sine of 2x away from each side of the equation. So let me write minus the inverse sine of 2x like this. And I'll just erase it from over here. And we'll just tighten this down. So I'll just move this down like this. Didn't grab everything. Let me try that again. Okay, so once again, what I like to do at this point is make a little substitution. So you have this guy right here, which again is an angle. So the inverse sine function gives you an angle from negative pi over 2 to pi over 2, with both of those being included. So I'm just going to let theta be equal to the inverse sine of 2x. And again, we can say that the sine of this angle theta is going to be equal to, again, here's your sine value. So that's going to be 2x. So let me rewrite this as the inverse cosine of x is equal to pi over 6 minus theta. So again, you can stop and make some restrictions and try to see if you can figure out, well, what quadrant is theta in? You can't always get it down to one quadrant, but you can eliminate some things and make your life a lot easier. So let me come down here a little bit and just say that, well, first off, we know that from this guy right here, theta is the inverse sine of 2x. Well, the inverse sine function gives me something from negative pi over 2 to pi over 2, with both being included. So I know that theta is greater than or equal to negative pi over 2 and less than or equal to pi over 2. Again, that's coming from the range of the inverse sine function. Now, when I think about this one right here, so for restriction 2, let me put and. I'll put number 2 here. Well, the inverse cosine function is going to give me something from 0 to pi. So let me say that this right here, this pi over 6 minus theta has to be, so pi over 6 minus theta has to be greater than or equal to 0 and less than or equal to pi. Just going to come to a fresh sheet where we have some room. So this one, again, you have to do some work. I would multiply everything by -1. So no change to this. This is going to flip. This is going to be negative, positive. This is going to flip. And then you're going to have a negative. So I'm going to rewrite this as theta minus pi over 6 is greater than or equal to negative pi and less than or equal to 0. Let me get rid of this. And to basically just add pi over 6 to each part. So add that here and add that here. So what is negative pi plus pi over 6? Well, you could write this as negative. So negative 6 pi over 6. So that would end up giving you negative 5 pi over 6. So let's say that theta is going to be greater than or equal to negative 5 pi over 6 and less than or equal to, well, 0 plus pi over 6, that's just going to be pi over 6. So pi over 6. Now we're going to look at this intersection. And basically, when you look at this left part here, you always want to go with the guy that is larger. So negative pi over 2 and negative 5 pi over 6, negative pi over 2 is larger or greater than negative 5 pi over 6. So I'm going to say this is negative pi over 2 is less than or equal to theta. And then on this guy right here, you want to go with the one that's smaller. So pi over 6 is less than pi over 2. So you're going to say and less than or equal to pi over 6. And let me paste this in and let's think about this for a second. We're saying that theta is greater than or equal to negative pi over 2 and less than or equal to pi over 6. So we're saying it's somewhere in there. If you're going to sketch a triangle, you could do this a lot of different ways. Some people will just sketch a triangle in quadrant 1 and then figure out the signs later. But I'll sketch a triangle in quadrant 1 and quadrant 4 and see if I can come up with all the information I need to solve the problem. So we know that we would take the cosine of each side, or again, you could just use the definition of the inverse cosine function. So if the inverse cosine of x equals pi over 6 minus theta, then the cosine of pi over 6 minus theta would be equal to x. Let me actually put the x over here. So x is equal to this. And this is getting a little bit busy, so let me put a little border here. And let's think about what we can do. Now, normally I write my difference identity for cosine. If you don't know it, again, the cosine of a minus b is equal to the cosine of a times the cosine of b And then basically this sign will be different. So it'll be plus, and then you have the sine of A, and then times the sine of B. So hopefully you can write that down and remember it. I know a lot of you already know it at this point. Let me get rid of it. And basically you're going to say that x is equal to, again, the cosine of the first guy, so the cosine of pi over 6, times the cosine of the second guy, so the cosine of theta. And then basically this is a plus. Now you have the sine of this first guy, so pi over 6, times the sine of the second guy, so the sine of theta. Now we know what the cosine of pi over 6 is, the sine of pi over 6 is, and the sine of theta is. If we go to the unit circle, pi over 6, you have a cosine value of square root of 3 over 2 and a sine value of 1/2. So this right here is the square root of 3 over 2, and this right here is 1/2. Now the sine of theta, again, is going to be 2x. So coming down here, this right here is 2x. So let's go through this. Now we have x is equal to the square root of 3 over 2 times the cosine of theta, and then plus we're going to have 1/2 times 2x, and so these 2's are going to cancel, so this is just plus x here. Now this is a bit strange, but basically you have x here and x here, so you can subtract x away from each side, and so you're going to say that the square root of 3 over 2 times the cosine of theta is equal to 0. Now you can multiply both sides by the reciprocal of this, or you could say you could divide both sides by the square root of 3 over 2. Basically, when you divide 0 by a non-zero number, it's going to be 0. So basically, you can get rid of this. Let me show this so nobody's lost. Let me multiply this by 2 over the square root of 3, and then times 2 over the square root of 3. So of course, this would cancel and give me a 1, and over here, this would be 0. So I'm just going to get rid of this. And basically, at this point, we say that cosine of theta equals 0. Okay, well, what is the cosine of theta? We know that the sine of theta is going to be 2x. Now, coming to a little sketch, let me rewrite that. So the sine of theta is equal to 2x. So you could say 2x over 1, where this is the opposite, and this is the hypotenuse. So why did I draw a triangle in quadrant 1 and 4? Again, because we said that theta was greater than or equal to negative pi over 2, and less than or equal to pi over 6. One thing is I know that the adjacent here is going to be positive, because whether I'm in quadrant 1 or quadrant 4, the traditional x values, not this x here, but the traditional x values, or the adjacent, that's going to be positive. So I know that once I do the Pythagorean theorem, and we saw this earlier, that this part right here would be the square root of 1 minus 4x squared. Again, just to go through it one more time, if you had an opposite of 2x, so 2x would be squared, plus an adjacent that's unknown, so let's just say the adjacent squared, that's equal to the hypotenuse, which is 1 squared, so that's just 1. So this is 4x squared. This is 4x squared. Don't forget to square each part. And then you just subtract that away from each side, so you get 1 minus 4x squared. And so we'll say the adjacent is equal to, again, I'm going to take the principal square root, so the square root of 1 minus 4x squared. So that's how I get this right here. So it doesn't matter whether I'm in quadrant 1 or 4, that would be my adjacent. So let's go ahead and say that the cosine of theta is equal to, the adjacent is the square root of 1 minus 4x squared. This is over the hypotenuse, but the hypotenuse is 1. So you could just write the square root of 1 minus 4x squared. Now let's go ahead and grab this real quick. So let's come back down here. And I'm just going to replace the cosine of theta with this right here, the square root of 1 minus 4x squared. And so let me just square both sides. And so 1 minus 4x squared would be equal to 0. Subtract 1 away from each side. This cancels. You get negative 4x squared is equal to negative 1. Let's divide both sides by negative 4. So this cancels. Let me drag this up here. You're going to get x squared is equal to, this would be positive 1/4. Now by the square root property, you're going to say that x is equal to plus or minus the square root of 1/4. So that's going to be plus or minus 1/2. So let's come back up to the top. And here we have, again, the inverse cosine of x plus the inverse sine of 2x is equal to pi over 6. So let's start with 1/2 and see if that works. So the inverse cosine of 1/2 plus the inverse sine of 2 times 1/2, so that would end up giving me 1. Does this equal pi over 6? Well, let's find out. What is the inverse cosine of 1/2? Most of you know that's pi over 3. What is the inverse sine of 1? Most of you know that's pi over 2. So this would be pi over 3, and then this would be pi over 2. Does that equal pi over 6? No. if you multiply this by 2 over 2 and you multiply this by 3 over 3, well, what's going to happen is you get 2 pi over 6 plus 3 pi over 6. Does that equal pi over 6? No, this is 5 pi over 6. If you come down here, this would be 5 pi over 6 is equal to pi over 6, so that is false. So the solution x equals positive 1/2 does not work. So let's plug in a negative 1/2 now. So the inverse cosine of negative 1/2 plus the inverse sine of 2 times negative 1/2. Does that equal pi over 6? So this would cancel, so you have negative 1 there. So again, a lot of you know this is negative pi over 2. And then for this one, you want a pi over 3 reference angle in quadrant 2, where cosine's negative. So that's going to be 2 pi over 3. So this is 2 pi over 3. And then basically you can put this as a minus here. So let me multiply this by 3 over 3. Let me multiply this by 2 over 2. And what you're going to have is 4 pi over 6 minus 3 pi over 6. Does that equal pi over 6? Yes, it does. You get pi over 6 is equal to pi over 6. And we are done with the problem. So we've checked, and we know that x equals negative 1/2 is the correct solution. So let me get rid of all this, and we'll go ahead and circle this one. So x equals negative 1/2. Okay, so once again, you can always sketch this graph on Desmos. So you can type in y equals the inverse cosine of x plus the inverse sine of 2x minus pi over 6. So I just took my equation and I subtracted pi over 6 away from each side. So this would be 0 over here. So if you plug in a 0 for y, the x value that makes that true is going to be your x-intercept and a solution for that equation. So that's going to be right here. Notice the x-coordinate is negative 0.5, or you could say that that's negative 1/2, comma, 0. So now that we've checked everything and we know that the solution is x equals negative 1/2, I just want to come back to this sketch for a moment. Remember, we knew that theta was greater than or equal to negative pi over 2 and less than or equal to pi over 6. Well, it ends up being that theta here is negative pi over 2. But if you didn't want to check and you wanted to say, okay, is x possibly positive 1/2? Well, I want you to think about this and then plug in a 1/2 and a negative 1/2 right there. And you're going to see that if you have the square root of 1 minus 4, and then you have x there being squared, well, it doesn't matter if it's negative 1/2 or positive 1/2. When you square that, you're going to get 1/4. So this right here turns into 1/4. And so 4 times a fourth is 1. You get 1 minus 1, which is 0, and the square root of 0 is 0. So that tells me that the adjacent is 0. So where is the adjacent 0? Well, at pi over 2 or 3 pi over 2, or again, if you're converting this over, you could say negative pi over 2. Okay, so that tells me that it can't be pi over 2 because, again, look at this right here. This theta here is greater than or equal to negative pi over 2 and less than or equal to pi over 6. So it can't be pi over 2. So it has to be negative pi over 2. So that means x has to be negative 1/2 and not positive 1/2. So that's another way you could have done it. I think maybe that's a little bit more thought than most people want to put into it. So probably just checking both solutions is the way to go. All right, let's take a look at the quiz. For the first question, we're asked to solve each for all solutions. We are given 4 secant of x plus 2 is less than 3 secant of x. Okay, let me grab this real quick. Come down here and paste this in. So for this type of problem, the first thing I would do is simplify it as much as I can. So I would just subtract 3 secant of x away from each side of this inequality. So this right here is going to cancel and give me 0 on the right. So I'm going to say that 4 secant of x minus 3 secant of x, that's going to just be the secant of x. So now I have the secant of x plus 2 is less than 0. Let me get rid of this real quick. And I'm just going to grab this and cut this away and come down to the unit circle. Now, a lot of you know the secant values already. So you can probably just look at the unit circle, or maybe you don't even need that, and you can put a solution together. But I think if you're just starting out with this, it's probably better to just solve the related equation and think about the solutions for that equation and then where this guy is going to be undefined. So in other words, find the critical values and then just test. I think that's the best thing you could do when you're starting out and you're working with something other than sine or cosine. So basically for this, I would solve secant of x plus 2 is equal to 0. And I would do this over the interval from 0 to 2 pi because the period for the secant of x is 2 pi. So this essentially would be the same as me saying the cosine of x is equal to basically negative 1/2. Now, where does that come from? Again, if you're not up to speed on this, you can say this is the secant of x is equal to -2, just by subtracting 2 away from each side of the equation. And then essentially, we know that the cosine of x is equal to 1 over the secant of x, and the secant of x is -2, so that's where I got cosine of x is equal to 1 over -2, or -1/2. Let's just put this as -1/2 for formatting like that. And essentially, if I'm solving this over the interval from 0 to 2 pi, 0 included, 2 pi excluded, I'm going into quadrants 2 and 3, where cosine is negative, and I'm going to look for an angle with a reference angle of pi over 3. So that's going to be 2 pi over 3. So there's your cosine value of -1/2. You would also have a secant value of -2. And then coming here, here's your 4 pi over 3. So there's your cosine value of -1/2. You would also have a secant value of -2. Let me get rid of this. I don't think we need this anymore. If you want to solve this equation, you would say that x is equal to, again, over this interval, 2 pi over 3. And then you would have 4 pi over 3. But again, when you find critical values, you also have to think about where things are undefined. Remember that if you look at y equals the secant of x, this is really y is equal to, the secant of x by definition is 1 over the cosine of x. So this would be undefined anywhere where the cosine value is 0. Well, working over this interval from 0 to 2 pi, 0 included, 2 pi excluded, that's going to be right here at pi over 2 and right here at 3 pi over 2. So we actually have quite a few intervals to go through, so this can be a little bit time consuming. But essentially, you're going to pick a value between 0 and pi over 2 and just plug it in, see if it works. Then between pi over 2 and 2 pi over 3, between 2 pi over 3 and 4 pi over 3, between 4 pi over 3 and 3 pi over 2, and then between 3 pi over 2 and 2 pi. Now, I've already set that up for us. We have the secant of x plus 2 is less than 0. So again, we're just going to plug in something from each interval, see what we get. If it's positive, it's rejected. If it's negative, it's accepted. So we'll just run through this. In this interval, I picked pi over 6. You can see you get about 3.15. I don't care what the number is. It's positive. And again, I'm looking for something that's negative, something that's less than 0. So this is out. Here I picked 7 pi over 12, which is going to be 105 degrees. And I get about -1.86 if I plug that in. This is negative, so that works. Here I'm picking 5 pi over 6. You plug that in, you get about 0.85. So this is positive, so again, I'm going to reject that. Then here I'm picking 17 pi over 12. That's 255 degrees. And essentially, you plug that in, you get about -1.86. So again, it's negative, so I'm going to accept that. And then lastly, here I'm going to pick 11 pi over 6. Plug that in. Again, you get about 3.15. It's positive, so I'm going to reject that. So essentially, to put the solution together, you have between pi over 2 and 2 pi over 3. So let me write this. So x is greater than, you have your pi over 2 and less than 2 pi over 3. And I'll do the plus 2 pi in a moment. Let me just tighten this down for right now. Then I'm going to put or right here. You're going to have your 4 pi over 3 is less than x, which is less than 3 pi over 2. And let me just paste this in. You have y equals secant of x plus 2. This is the graph in blue. And essentially, we're trying to figure out where the secant of x plus 2 is less than 0. So where are the y values less than 0? So basically, you see this first part here, x is greater than pi over 2. This right here, this vertical asymptote, well, the x value there, this is the line. If you think about this as a vertical line, this is x is equal to pi over 2. So that's a vertical asymptote there. And that's going to happen because, again, at pi over 2, the cosine value is 0. So this approaches negative infinity, and this approaches positive infinity. Now, if you look at this vertical asymptote here, this is going to be x equals 3 pi over 2. So look at your solution. You're saying x is greater than pi over 2. So greater than pi over 2 and less than 2 pi over 3. This right here is 2 pi over 3. Let me highlight that. So this right there is 2 pi over 3. And then over here, this is basically x is greater than 4 pi over 3. This is 4 pi over 3 and less than 3 pi over 2. So in each case, you're picking a place on the graph where essentially the y values are less than 0. So you want this piece of the graph right there and this piece of the graph right here. Now, essentially, because the secant of x has a period of 2 pi, things are going to repeat every 2 pi. So if I slide down on the graph, what you're going to see is that, well, if you take 2 pi over 3 and you add 2 pi, so you're adding 6 pi over 3, that's going to give me 8 pi over 3. If you take 4 pi over 3 and you add 6 pi over 3, again, just adding 2 pi, that's 10 pi over 3. So again, you'd have the same thing happen here. So basically, This right here is x equals 5 pi over 2. Let me arrow to that. And this right here is x equals 7 pi over 2. So this is a vertical asymptote, and this is a vertical asymptote. And essentially, this piece right here, where x is greater than this 5 pi over 2 and less than 8 pi over 3, that's going to work again. The y values are less than 0. Then this piece right here, where x is greater than that 10 pi over 3 and less than that 7 pi over 2, again, the y values would be less than 0. I'm just going to paste this in, and I'm just going to rewrite this to put the period in. So x is greater than, you want pi over 2 plus 2 pi n, and you're going to say, and it's less than, you want 2 pi over 3 plus 2 pi n. All right, so that's that one. Then you're going to use your keyword or. So or, x is greater than, again, use your 4 pi over 3 plus your 2 pi n, and it's less than, you're going to go 3 pi over 2 plus 2 pi n. So n is any integer there. Now, looking through the choices, it's going to be this one right here. So pi over 2 plus 2 pi n is less than x, which is less than 2 pi over 3 plus 2 pi n. Or, and again, you have your 4 pi over 3 plus 2 pi n is less than x, which is less than 3 pi over 2 plus 2 pi n, again, where n is any integer. Okay, let's take a look at question 2. So again, we want to solve each for all solutions. So we have here that the tangent of x plus -9 plus the square root of 3 over 3 is greater than -3. Again, if you have something that's not sine or cosine, typically you want to use a table or some sort of test point approach. It's up to you how you set that up. Some people know the tangent values very well, so you can just do it that way, and you don't have to use a table. But again, if you're starting out, I recommend a table. So the first thing I would do here is just clean up. So I would get rid of this denominator of a 3, and I would multiply everything by 3 to do that. So you'd have 3 tangent of x plus 3 times -9 plus the square root of 3 over 3. This is greater than -3 times 3. Okay, let me slide down a little bit. So of course, these 3's are going to cancel, and you're going to have your 3 tangent of x, and then -9 plus the square root of 3 is greater than -3 times 3 is -9. Now, of course, we have -9 here and -9 here, so I can add 9 to both sides of the inequality. And so this is going to cancel, and this is going to cancel, and I get 0. Let me slide down here a little bit and say that we have 3 tangent of x plus the square root of 3 is greater than 0. So what I would do, again, is solve the related equation and then think about my critical values. So what are the solutions from the equation, and then where's it undefined? Let me come down here a little bit. Let's just set up the equation. So basically, let's say if we had 3 tangent of x plus the square root of 3, where's that equal to 0? Well, subtract the square root of 3 away from each side. So this 3 tangent of x would be equal to the negative of the square root of 3, and then divide both sides by 3. So this right here would cancel away. Now, we can go to the unit circle. Although the tangent values are not directly there, we can check things with it. So let's just go ahead and grab this. I think most of you know that if you did the inverse tangent of, let's just make this positive, so the square root of 3 over 3, you're going to get pi over 6. Of course, you can check this on the unit circle. So tangent of pi over 6 is the sine of pi over 6, which is 1/2, divided by the cosine of pi over 6, which is square root of 3 over 2. So multiply by the reciprocal, so times 2 over the square root of 3. And so essentially these cancel, and you get 1 over the square root of 3. So times the square root of 3 over the square root of 3. So this becomes the square root of 3 over 3. So basically what you want to do is go into quadrants 2 and 4, where the tangent values are negative, and look for an angle with a reference angle of pi over 6. So that's going to be 5 pi over 6, so right here. And basically, you're going to have 11 pi over 6, so right here. So if you're going to work in the interval from 0 to 2 pi, a lot of times we do that, those are the solutions you're going to list. Now, we know that the period for tangent is pi. So essentially, you have a solution here, you add pi, you get to another solution, so you're right there, add pi, you're back to another solution, so on and so forth. So what I'm going to do is get rid of this and just say that x is equal to, I'm just going to put the 5 pi over 6, and we're just going to solve from 0 to pi, because again, the period for tangent is pi, so that's all we need. So I'm going to include 0 and exclude pi. Now, this is going to make it a little bit tricky, and you're going to see why. So maybe you want to go out to 2 pi. It might make it a little bit easier. I'll show you that in a moment. So basically, what you're going to do is also think about, where is this guy undefined? So the tangent of x, again by definition, is the sine of x over the cosine of x. Well, over this interval, where's the cosine value 0? Well, it's going to be right here at pi over 2. So basically, that gives me a few intervals. So I'm going to go between 0 and pi over 2, between pi over 2 and 5 pi over 6, and then between 5 pi over 6 and pi. So let's just look at that real quick. I'm just going to erase everything here. We're going to need the room when we come back so I can explain everything. So here's the table already set up. So we're going back to the inequality. So 3 tangent of x plus square root of 3 is greater than 0. So again, I want to know where this is positive. So in the first interval, I'm picking pi over 6, and I get about 3.46. Again, I don't care what the value is, just that it's positive. So I know that interval, it's going to work. Then in the second interval, I'm going to pick 3 pi over 4. You notice that this is about negative 1.27. Again, I don't care what the value is. It's negative, so this is not going to work. Then in this interval here, I'm going to pick 11 pi over 12. So that's going to be 165 degrees, in case you're curious. And you plug that in and you get about 0.93. So again, this is positive. So I'm just going to take that one. Now, the solution here is going to be a bit strange to put together, and there's actually different ways to do it. So let me go back up. So if you go by what we did, so between 0 and pi over 2, so between 0 and pi over 2, and basically there's nothing stopping 0 from working, but I'm going to leave it off for right now. This interval right here does not work, and then this interval does work. Now, 5 pi over 6 would be excluded because that makes it 0, and we want greater than 0. Pi over 2 is undefined, so that's excluded. Now, I'm going to think about this piece right here, and what I'm going to do is bring it over here. So in other words, if I took 0 and I added pi, the period, I would get to pi. Let me actually go ahead and say that this is included, and so this would be included. And then basically, this is going to go to pi over 2, so here, this right here is going to go to 3 pi over 2. But basically, this is not included and this is not included because that's where it's undefined. So let me draw this as a continuous piece right here. So that right there, and I'm going to stop short. So let me circle this and circle this to show it's not included. Then this piece right here from 5 pi over 6 to pi, again, this is excluded. Let me circle that. I can add pi to that. So 5 pi over 6 plus pi, that's 11 pi over 6. And essentially, I'm going to shade all of this. So it's important to note what's included and what's excluded. So 5 pi over 6 and 11 pi over 6, again, that makes it 0. We want greater than 0. So those are not included. 3 pi over 2 and pi over 2, that's where it's undefined, so it's not included. So basically, this right here or this right here, you'll see this when you get to the graph. So essentially, you could write this in different ways. One way that you could write it, again, you could put in a negative rotation here and say this is negative pi over 6. So you could say that x is greater than negative pi over 6 plus pi n, and I never leave enough room, so plus pi n, and it's less than, this would be pi over 2 plus pi n. You could also write this as 11 pi over 6, but when you get up here, this is not pi over 2, it's pi over 2 plus 2 pi, or basically pi over 2 plus 4 pi over 2, which is 5 pi over 2. So you could say that x is greater than, you could go 11 pi over 6 plus your pi n, and it's less than, again, this would be 5 pi over 2, so 5 pi over 2, and then plus pi n. So another way to write the solution. This is what I listed in the quiz. So you could say that x is greater than 5 pi over 6 plus pi n, and less than, this would be 3 pi over 2 plus pi n. Okay, let's grab this real quick. And again, I have this graph set up for you on Desmos already. Just click the link. And basically, you see that in red here, you have y equals 3 tangent of x plus square root of 3. So the x-intercepts, I've highlighted a few of them and labeled them. You just have to be careful about where it's labeling it and what it is. You can hover over it. So this right here is 5 pi over 6 for the x value. That's an x-intercept. Here is 11 pi over 6. If you did this one, it would be negative pi over 6. If you keep going down, if you added pi to this, you're adding 6 pi over 6. So this right here would be 17 pi over 6. So 17 pi over 6. And essentially, you can look at each one and use any of them for the solution. Essentially, you're just taking this piece right here. So I'm taking anything that's greater than 5 pi over 6. And basically, we're going to go where we're less than. This right here, this vertical asymptote, this is x equals 3 pi over 2. So that's where we're getting this right here. So x is greater than 5 pi over 6 plus pi n and less than 3 pi over 2 plus pi n. Again, if you wanted to, going back to what we did on the unit circle, this right here, this is negative pi over 6. That was rotating clockwise, and then comma 0. And then essentially, you can go from here, anything greater than that, well, the y values are greater than 0. basically going up to and excluding this vertical asymptote here, this is going to be x is equal to, that's your pi over 2. So again, if you want to do it that way, that would be fine as well. Well, let's go ahead and grab this real quick. Come back up here and paste this in. So essentially, I'm looking for this right here. So x is greater than 5 pi over 6 plus pi n and less than 3 pi over 2 plus pi n, where n is any integer. All right, let's take a look at question 3. So here we want to solve each for all solutions, and we have negative 8, and then cosine of, you're going to have x minus 4 pi over 3, and this is less than negative 4. Let me slide this down so it fits, and then times your square root of 3. Come down here. This one's pretty easy. You're just going to make a substitution. Before I do that, let me divide both sides of the inequality by negative 8. Now this is huge here. Remember, if you divide both sides by a negative, you have to flip the direction of the inequality symbol. So don't forget to do that. So this right here would cancel, and you're going to have the cosine of this x minus 4 pi over 3. This would now be greater than, because we're flipping the inequality symbol. And so negative 4 over negative 8, negative over negative is positive. 4 over 8 is 1/2. So essentially, this is just the square root of 3 over 2. Okay, so when we make our substitution, we're going to make our life a lot easier. Basically, all you have to do is say, we're going to let something like u be equal to this inside part. So that's going to be equal to x minus 4 pi over 3. That's all we're going to do. So now we're going to solve cosine of u is greater than square root of 3 over 2. So that's really easy to do. You don't need any kind of table, although you can use one if you prefer that. Let me just paste this in here real quick. So where's the cosine value going to be square root of 3 over 2? In other words, cosine of u equals square root of 3 over 2 over the interval from 0 to 2 pi, 0 included, 2 pi excluded. U is equal to what? Well, essentially, we know that cosine is positive in quadrants 1 and 4. And I'm looking at pi over 6 here. That's my square root of 3 over 2 for the cosine value. And in quadrant 4, I want an angle with a reference angle of pi over 6. So 11 pi over 6, there's my square root of 3 over 2 for the cosine value. So let's say that this is pi over 6, and then this is 11 pi over 6. And you can list this, you really don't need it. You're trying to figure out where the cosine values are greater than square root of 3 over 2. So if you look between here, that's where that's going to happen. So in other words, right here, like this. If you look outside of that, well, basically the cosine values are less than square root of 3 over 2. So putting the solution together is a little bit tricky, as we've seen before. Let me get rid of this. We're basically going to say, again, this is in terms of u. So u is greater than, you can use this 11 pi over 6 if you want, or you can rotate clockwise and say it's negative pi over 6. I'm just going to use the 11 pi over 6. Again, you just have to make the adjustment. So this is 11 pi over 6. In terms of u, the period is 2 pi. So plus 2 pi, and again, didn't leave myself enough room. So 2 pi n. So let me put that back in. We'll say, and it's less than, again, this is not pi over 6. You have to take pi over 6 and add 2 pi. So we're going to add 12 pi over 6. So that's 13 pi over 6. So let's say now that this is 13 pi over 6. Let me get rid of this scratch work here so we can write it more neatly. Slide this over, and I'm going to put plus 2 pi n. Okay, let me grab this. We have this in terms of u, and we want it in terms of x. So all you have to do, let me actually erase this. Just put this in the middle. We had u there. Let me put x minus 4 pi over 3. Let me go back to is less than. We had 13 pi over 6, and then plus 2 pi n. Okay, to solve for x, all you have to do is add 4 pi over 3 to each part. So real simple. So let me do that over here. And I think we can just do that off to the side. So 11 pi over 6 plus. For 4 pi over 3, you need a common denominator. Let me just show that. So 4 pi over 3 times 2 over 2. So this would be 8 pi over 6 that you're adding. So 8 pi over 6. So 11 pi plus 8 pi is 19 pi. So this will end up being 19 pi over 6 plus 2 pi n. This cancels, so this is less than x, which is less than. You have 13 pi over 6 plus 4 pi over 3. Again, you can write that as 13 pi over 6 plus 8 pi over 6, just getting a common denominator. Again, multiplying this by 2 over 2. 13 pi plus 8 pi, that's going to be 21 pi. So this would be 21 pi over 6. Now, 21 and 6 are each divisible by 3. 21 divided by 3 is 7, and 6 divided by 3 is 2. So this would be 7 pi over 2. And then plus your 2 pi n. So let's go ahead and grab this real quick. Okay, let's come down here and look at this solution on the graph. So again, you can visit Desmos with that link I gave you. Remember that we divided both sides by a negative, so the inequality symbol flipped. We have y equals cosine of this x minus 4 pi over 3 minus the square root of 3 over 2. You're now looking for y values that are greater than. Again, the inequality symbol switched because we divided both sides by a negative. So one way you can do this, and this is how the solution is actually written, you have between 7 pi over 6 and 3 pi over 2. Again, those values there are coming from subtracting 2 pi away from each guy here. So 19 pi over 6 minus 2 pi would give you 7 pi over 6. 7 pi over 2 minus 2 pi would give you 3 pi over 2. Again, between these values, that's where you're going to have y values that are greater than 0. If you slide down here, you're going to see the solution we came up with. So this is perfectly valid as well. So you could have 19 pi over 6 there and 7 pi over 2 there. And again, between those values, the y values are greater than 0. So let me slide down here. I'm just going to rewrite the solution for the practice test, how we have it. So we're going to say that x is greater than. So you'd have your 7 pi over 6 plus 2 pi n. And it's less than, you're going to do 3 pi over 2 plus 2 pi n. So once again, lots of different ways to write your solution. Let me paste this in. So I'm going to be looking for this one right here. So basically, x is greater than 7 pi over 6 plus 2 pi n and less than 3 pi over 2 plus 2 pi n, where n is any integer. All right, let's take a look at question 4 now. So again, we want to solve each for all solutions. We're going to look at the square root of 2, and then we have sine of x minus 2 sine of 2x. Let me move this over so it fits. This is greater than or equal to negative 3 and then sine of 2x. Okay, let me grab this real quick and come down here. So definitely with this problem, we're going to use the test point approach. The first thing I'm going to do is just clean this up before I try to do anything else. So I'm going to add 3 sine of 2x to both sides of the inequality. So that's going to help us out quite a bit. So basically this will cancel and give me 0. So you can have the square root of 2 and then sine of x. You have negative 2 sine of 2x plus 3 sine of 2x. That's going to be plus sine of 2x. And this is greater than or equal to 0. All right, so I'm just going to solve the related equation. When you test, you can use this form or the other form I'm going to generate. So basically, I'm going to go square root of 2 sine of x plus the sine of 2x. Remember, you have an identity for that. So the sine of 2x is, you only have one of them. It's going to be 2 sine of x cosine of x. So basically, I'm just going to plug this in for this. So let's put 2, and then you're going to have sine of x and then cosine of x. And we're going to say that's equal to 0. We're just going to solve the related equation. So again, when you test, you can put it like this, or you can plug this in for this, whatever you want to do, whatever you're more comfortable with. So if you wanted to solve this, what would you do? Well, I would solve it with factoring. And basically what I would do is I would pull out the square root of 2 sine of x. Let me actually slide this down a little bit so I can change this form here so you can see what I mean in case you're a little bit lost. So instead of 2, I'm going to write this as the square root of 2 times the square root of 2. We know that's 2. And so essentially you have square root of 2 sine of x and square root of 2 sine of x, and that is what I'm pulling out. So essentially that comes out in front of some parentheses. So you have your square root of 2 sine of x times the quantity. So inside, if I pull this out, I'm just going to have a 1 and then plus. If this gets pulled out, you have square root of 2. So square root of 2 and then cosine of x. Close that down and this equals 0. So the first one is going to be square root of 2 sine of x is equal to 0. Divide both sides by the square root of 2, and you just have sine of x equals 0. Then I'm going to go or. We're going to have 1 plus the square root of 2 cosine of x is equal to 0. Subtract 1 away from each side. So basically, square root of 2 cosine of x is equal to negative 1. Divide both sides by the square root of 2, and this would cancel. So let's say the cosine of x is going to be equal to the negative of 1 over the square root of 2, which is negative square root of 2 over 2 if you rationalize the denominator. So let me go ahead and grab this real quick and paste this in. So basically, you're going to solve this over the interval from 0 to 2 pi. Let's just take this form here. It's easy to think about it. You have sine of x and sine of 2x. So the period for the sine of 2x is pi, and the period for the sine of x is 2 pi. So the least common multiple of pi and 2 pi would be 2 pi. So in other words, if you graph y equals square root of 2 sine of x plus sine of 2x, you're going to see the period is 2 pi. So when I look at this guy, basically I would just solve it over the interval from 0 to 2 pi, and basically over the next interval, you could say from 2 pi to 4 pi, things would repeat. So where's the sine of x equal to 0? Well, essentially that's going to be at 0. So there the sine value is 0. And then also at pi. So in that interval that we're working with, where's the cosine of x equal to negative square root of 2 over 2? Well, I want a pi over 4 reference angle in quadrants 2 and 3, where cosine is negative. So that's going to be right here at 3 pi over 4. There's your negative square root of 2 over 2 for the cosine value. And then 5 pi over 4, again, there's your negative square root of 2 over 2 for the cosine value. All right, so looking at this, again, I'm going to set up an interval between 0 and 3 pi over 4, and then between 3 pi over 4 and pi, between pi and 5 pi over 4, and then between 5 pi over 4 and 2 pi. All right, so I've already set up the table. So again, I chose a different form here. If you want to write this part as plus sine of 2x, that's fine. It's the same thing. So basically, if I look in this first interval, I'm picking pi over 6, and I plug it in, I get about 1.57. That is greater than 0. So let me go ahead and say this works. In the next interval, I pick 5 pi over 6. I get about negative 0.16. So again, this is negative, so it's not going to work. In the next interval, I pick 7 pi over 6. This is about 0.16. Again, it's positive, so this is going to work. And in the next interval, I pick 11 pi over 6. I get about negative 1.57. So again, this is negative, so it's not going to work. So basically between 0 and 3 pi over 4, and then also between pi and 5 pi over 4. So between 0 and 3 pi over 4, and then between pi and 5 pi over 4. So in terms of the critical values, they're going to work because this is a non-strict inequality. So at 0, we would get 0 equals 0, so that's a true statement. Same thing for 3 pi over 4, and then pi, and then 5 pi over 4. So basically, the way you want to put this solution together, let me erase all this. So let me start with x is greater than or equal to. Again, you can go 0 plus 2 pi n, but that's just 2 pi n. So let me write 2 pi n. We'll say and it's less than or equal to. Over here, we have this 3 pi over 4. So let me put 3 pi over 4, and then plus 2 pi n. Then I'm going to go or. So we need this part right here. So we're going to say x is greater than or equal to. You have your pi, so pi plus 2 pi n, and it's less than or equal to. Over here, we have 5 pi over 4, so 5 pi over 4, and then plus 2 pi n. Okay, let's grab this real quick. And again, I've already graphed this on Desmos. I have y equals square root of 2 sine of x plus 2 sine of x cosine of x. And so let me paste in this solution so we can see it. Let me get rid of this highlighting here. And again, you can follow it on Desmos if it's hard to see. But essentially, if you're looking for the x-intercepts, or where this guy is 0, you have one at 0, then 3 pi over 4, then pi, then 5 pi over 4. And then you see at 2 pi, basically this one's repeating. So if you go into this next section, you have 2 pi, which is 0 plus 2 pi. You have 11 pi over 4, which is 3 pi over 4 plus 2 pi. We have 3 pi, which is pi plus 2 pi. And if we keep sliding over, we have 13 pi over 4, which is 5 pi over 4 plus 2 pi. And then you have your 4 pi, which is 2 pi plus 2 pi. Okay, so let's slide back. And again, you see the parts that work. So basically where we're greater than or equal to 0, so the x-intercepts work. But essentially this piece right here, we're going to be greater than 0. So between those values, and of course, the 0 and 3 pi over 4, those work. So that's where this one comes from. So x is greater than or equal to 2 pi n. So that's 0 plus 2 pi n, and less than or equal to 3 pi over 4 plus 2 pi n. So that's this part right here. Then the other part is this part right here. So this is your pi, and this is your 5 pi over 4. So this right here, it's going to work again between those values and including them. So x is greater than or equal to this pi plus 2 pi n, and less than or equal to 5 pi over 4 plus 2 pi n. Okay, let's grab this real quick. Let's come down here and look through what we have. So it looks like we're going to want this one right here. So the x is greater than or equal to 2 pi n, and less than or equal to 3 pi over 4 plus 2 pi n. Then or we have x is greater than or equal to pi plus 2 pi n, and less than or equal to 5 pi over 4 plus 2 pi n, where n is any integer. All right, for question 5, we're asked again to solve each for all solutions. And we're given negative 2 cosine of x plus 4 sine of x over 2. This is less than negative 3. Come down here and paste this in. So what I would actually do is add 3 to each side. So let's say this is plus 3 is less than 0. All right, you know that I don't like using the half angle formula. The reason is because when you square both sides, you have to check. So what I'm going to do is replace this with equals. And I'm going to use a double angle formula, so I have to use a substitution technique for that. So let's go -2 cosine of x plus 4 sine of x over 2 plus 3 is equal to 0. And essentially what I'm going to do here is let something like u be equal to this x over 2. So x over 2, and we know that then if we multiply both sides by 2, this would be 2u is equal to x. So 2u is equal to x. I'm just going to erase this and put 2u, and then erase this and put u. Okay, let me grab this real quick. We're going to keep this here. We're not going to need it. We're going to see that it's no solution, but we'll just keep it here. Let me come down here and paste this in. If you want to solve this, remember for cosine of 2u, so for cosine of 2u, one formula we have is 1 minus 2 sine squared u. So I'm going to plug this right here in for this right here. So you got to be really careful because you're multiplying it by -2. So let me show this as matching this. Okay, so let's be careful. We have -2 out in front. I'm going to wrap this inside of parentheses. So 1 minus 2 sine squared u, close that down, then plus 4 sine of u, and then plus 3, and this equals 0. Okay, let me make this 3 a lot better. All right, let me distribute this -2 to each guy inside of the parentheses. You're going to have -2 times 1, that's -2, and then -2 times -2 sine squared u is plus 4 sine squared u. And then we have plus 4 sine of u, and then plus 3, and this equals 0. Okay, so we're going to basically look at -2 plus 3. That's going to be positive 1. So let me write this as a 1 here. And we're going to try to solve this with factoring. So essentially, what you're going to do is turn this into, let me put a 2 sine of u here and a 2 sine of u here. Now you could try 4 sine of u and then sine of u, but that's not going to work. So basically you're going to see that this is going to end up being a quantity squared. If you go plus 1 here and plus 1 here, this is what's going to work. This outer here is 2 sine of u, and you could put plus there if you want. And this inner here is plus 2 sine of u. So 2 sine of u plus 2 sine of u, that's 4 sine of u. So this is what we want for the factorization. So really you can put this as quantity squared is equal to 0. Now, do we even need to bother solving this equation? No. Let me explain why. Let me actually grab this real quick and come back up here. So I'm going to paste this in. So essentially, all I did, if you forget about the fact that this is x for a moment, and let's just say you plug this in and say this is 2u. Let me slide this over here and say this is 2u. And let me plug this in right here as u. So essentially what I'm saying is that I can replace this through a process of using identities like we did a moment ago and basically say that this right here is less than 0. Is that ever going to be true? No, absolutely not. And the reason is because this quantity right here is squared, and something squared is either going to be 0 or some positive value. It will never be less than 0. So it doesn't matter if you substitute x over 2 back in or something like that. That's not going to make a difference. This will never, ever, ever be true. So basically, this is no solution. Okay, and if you want to go through this the long way, you can, of course. You could solve the related equation, set up your intervals, and do the testing, but you're going to see that it's not going to work anywhere. So you're going to come back and be a little bit confused. This is the best way, I think, is just to stop right now and say, okay, well, this right here is squared, and that can never be less than 0, so there's no solution. If you want to look at the graph of this guy, again, I gave you a link on Desmos, so just looking at what we started with, where is that less than 0? Well, it's never less than 0. It's either 0 or it's greater than 0, everywhere on the graph. So you can look at that for yourself on Desmos, but you're going to see that there's no y value here that's ever going to be less than 0, so there is no solution. So coming back, I just want to select no solution. All right, let's take a look at the section quiz. For the first question, we're asked to find the exact value, and we have the inverse secant of the negative of the square root of 2. So let me grab this real quick and come down to the unit circle. So what I'm going to do is convert this over into a problem that uses the inverse cosine function. So the inverse cosine of, you're just going to take the reciprocal of this argument here. So that would be the negative of 1 over the square root of 2. And of course, you can rationalize the denominator there. So let me say this equals the inverse cosine of the negative of I'm going to multiply the numerator and denominator by the square root of 2. So you'd have the square root of 2 over 2. So I'm just going to erase this form here. And let me just drag this up. Now, when I think about the inverse cosine function, again, I'm getting something from 0 to pi, with both being included. So basically, you're going to look for a cosine value of negative square root of 2 over 2, and that's going to happen right here. And the associated angle is going to be 3 pi over 4. So the inverse secant of the negative of the square root of 2 is going to be equal to the inverse cosine of the negative of square root of 2 over 2, which is going to be equal to 3 pi over 4. So let's come back up and answer 3 pi over 4. All right, for question 2, we're again asked to find the exact value, and we have the inverse sine of the cosine of pi. So let me grab this. Again, if we think about this on the unit circle, we want to think about what is the cosine of pi first. So pi is going to be right here, and your cosine value is negative 1. So basically, you're going to replace the cosine of pi with negative 1, and now you have the inverse sine of negative 1. Remember that for the inverse sine function, you're working from negative pi over 2 to pi over 2, with both of those being included. And so where would I have a sine value of negative 1? Well, it's going to be right here. But again, remember, you don't want to take 3 pi over 2. You need to rotate clockwise. So you want this guy right here. So that would be negative pi over 2. So you could put 3 pi over 2 like this and just subtract away 2 pi. So subtract away 4 pi over 2. So you have a common denominator. So that gives you negative pi over 2. Again, you can always just do it using the unit circle like this, or it's something you can memorize. Again, lots of ways to think about this, but the answer is just negative pi over 2. So coming back up, I just want negative pi over 2. All right, let's take a look at question 3. We're asked to find the exact value. So here we have the inverse tangent of the tangent of negative 16 pi over 3. So a lot of students will make the mistake and just cancel this with this and say negative 16 pi over 3 is the answer, but it's not. Remember that if you have something like the inverse tangent of the tangent of, let's say, x, this is equal to x, but only for x being strictly greater than negative pi over 2 and less than pi over 2. You could think about this interval here coming from the domain of the restricted tangent function or the range of the inverse tangent function. So in this particular case, this negative 16 pi over 3, that's not in this interval. So what you could do is you could evaluate the tangent of negative 16 pi over 3 first, and then take the inverse tangent of that. That's one strategy. I think that's a little bit slower than what I'm going to do. So what I would do is actually put this in terms of the coterminal angle. So let me come down here to the unit circle so you can see what I'm doing here. So if I think about negative 16 pi over 3, I want to find the coterminal angle. So I'm just going to add, well, you could do 2 pi, which is 6 pi over 3, but that's really not going to do you any good. You could then go to 12 pi over 3, which is 4 pi, still not going to get you there. So I would add 18 pi over 3, which is 6 pi. So 18 pi over 3, which again is 6 pi. So this would give me 2 pi over 3. So that tells me I'm going to be right there. Now again, when I think about the inverse tangent function, I'm working from negative pi over 2 to pi over 2, with both of those guys being excluded. Okay, so let me show that there. So what you could do, again, since we know the period for tangent is pi, you could just swing yourself around by pi, and that's going to put you right there at 5 pi over 3. So I know that the tangent of 2 pi over 3 is equal to the tangent of 5 pi over 3. Now, 5 pi over 3 is not what I want because that's not in the interval from negative pi over 2 to pi over 2, with both being excluded. So what you want to do is actually take that 5 pi over 3 and subtract away 2 pi, or you can think about it as just saying that I'm going to start here and rotate clockwise, and that angle I want is negative pi over 3. Again, you could take 5 pi over 3 and subtract away 6 pi over 3. That's going to give you negative pi over 3 as well. So really, the way that I would do this, and I know it took a while to explain, but the way that I would do this if I got the problem was to say the inverse tangent of the tangent of negative 16 pi over 3, let me make that a little bit better, would be equal to the inverse tangent of, I'm just going to take this guy right here and say that, well, the tangent of negative pi over 3 is the same as the tangent of negative 16 pi over 3. So I'm just going to say this is the tangent of negative pi over 3. And now this right here is in the interval from negative pi over 2 to pi over 2, with both being excluded. So I can just say that these guys will undo each other, and the answer here is negative pi over 3. So coming back up, I want to select negative pi over 3 as my answer. All right, let's take a look at problem 4. Here we're asked to find the exact value. And what we have is the sine of the inverse tangent of the square root of 11 over 2. So remember that this right here is an angle, and it's going to be in quadrant 1 because the argument is positive here. So what I would do is make a little substitution. I would let something like theta be equal to this inverse tangent of square root of 11 over 2. And then what you can do is say that the tangent of theta is equal to the square root of 11 over 2. So again, I know that theta is in quadrant 1 because you have a positive argument for your inverse tangent function, so that gives you an angle in quadrant 1. Now additionally, I know that from the definition of the tangent of theta, that this is going to be the opposite over the adjacent. Now if I want the sine of this angle right here, which is represented with theta, well basically to find the sine of theta, I want the opposite over the hypotenuse. Well, the opposite is the square root of 11. So the square root of 11, I just need to figure out what is the hypotenuse. So again, you can use your Pythagorean theorem. You can also make a sketch if that's helpful. So this is your angle theta. This is your opposite, which is square root of 11. And this is going to be your adjacent, which is 2. And if you use the Pythagorean theorem, you can find your hypotenuse, which is the square root of 15. So basically 2 squared plus the square root of 11 squared is equal to, let's just call this r. So r squared. So this would be 4 plus 11 is equal to r squared. So let's say r squared is equal to 15. And then again, this is always going to be positive. So we say r is equal to the principal square root of 15. So coming back, I'm just going to erase this and put a square root of 15 in there. Now we don't see the square root of 11 over the square root of 15 as an answer. And the reason is that we want to rationalize the denominator. So I'm going to multiply this by the square root of 15 over the square root of 15. So this would be square root of 11 times square root of 15 is the square root of 165. And then square root of 15 times square root of 15 is 15. So basically the sine of theta, or you could say the sine of the inverse tangent, so the inverse tangent of this square root of 11 over 2 is going to be equal to the square root of 165 over 15. So this guy right there. All right, for question 5, we're asked to find the exact value. And here we have the tangent of the inverse sine of the square root of 10 over 10. So again, just like the last problem, we're just going to let something like theta be equal to this right here. This is an angle in quadrant 1. Remember, you know that because this argument here for the inverse sine function is positive. So let theta be equal to the inverse sine of the square root of 10 over 10. And then you can say that the sine of theta is equal to this square root of 10 over 10. And of course, theta is in quadrant 1. Now this right here is going to be your opposite, and this right here is going to be your hypotenuse. Now we're asked for the tangent of, again, this angle is represented with theta. So what is the tangent of theta? Again, this is opposite over adjacent. So I just need to figure out what is the adjacent. Again, you can make a sketch if you want. So it would look something like this. So we know that the opposite is square root of 10. We know that the hypotenuse is 10. And so with the Pythagorean theorem, we can figure out that the adjacent is 3 times square root of 10. So just going through this real quick, we would know this one and this one. So let's say we have the square root of 10 being squared, plus let's call this x, so x squared. And this equals, this guy's going to be 10, so 10 squared is 100. So basically the square root of 10 squared is 10. So this is 10. If I subtract that away from each side, you would have 100 minus 10, that's 90. And then basically x is going to be the principal square root of 90. So x is the principal square root of 90. And of course, you can break that up into 9 times 10. And the square root of 9 is 3. So this becomes 3 times the square root of 10. So that's how I got that there. So coming back, I know that the adjacent is 3 times square root of 10. And I know that the opposite, again, is the square root of 10. And of course, this would cancel with this and give me a 1 up here. So the tangent of theta is 1/3. Or you could write it in terms of the problem, and you could say that the tangent of the inverse sine of the square root of 10 over 10 is going to be 1/3. So we want this guy right here, this 1/3, as our answer. All right, let's take a look at question 6 now. So we're asked to find the exact value. So here we have the cosine of the inverse tangent of the square root of 3. What I would do is just replace that now. We know that that's pi over 3. So let me write in that that's pi over 3. And then plus, here we have the inverse sine of 1/3. So let me go ahead and grab this real quick. Come down here and paste this in. Whenever I get a problem like this, I like to use a little substitution. Again, you don't have to, but I'm going to let theta be equal to the inverse sine of this 1/3. So I know that theta is an angle in quadrant 1 because, again, this argument is positive here for the inverse sine function. And then you can say that the sine of this angle theta is equal to 1/3. Let me put a little border here and say that theta is in quadrant 1. Okay, so making a replacement here, I'm going to say that I want the cosine of pi over 3 plus, again, I'm going to call this theta. So close that down. So for this one, you just use your sum identity for cosine. So hopefully you remember that. It's the cosine of the first guy. So you want the cosine of pi over 3. And then times the cosine of the second guy. So the cosine of theta. And then the sign here is different. Here it's a plus, so it's going to be a minus. And now you're going to do the sine of the first guy, which is pi over 3. And then times the sine of the second guy, which is theta. Well, there's a few things I can replace. I know that the sine of theta is 1/3. It's given to me right there. So I'm just going to erase this and put in a 1/3. Then the sine of pi over 3, I know that that's square root of 3 over 2. So this right here is square root of 3 over 2. And then the cosine of pi over 3, that is 1/2. So this right here is 1/2. So I just need to figure out what is the cosine of theta. So let me put a little border here real quick and say, what is the cosine of theta? The cosine of theta is the adjacent over the hypotenuse. Well, right now, I know that the sine of theta is going to be 1/3, and this is the opposite over the hypotenuse. Okay, well, I know the hypotenuse is 3 then. I just need to figure out what is the adjacent. Again, you can make a sketch. You can just use the Pythagorean theorem. It's up to you. But you know your opposite is 1, and your hypotenuse is 3. So your adjacent is going to end up being 2 times square root of 2. So again, if you want to do this, we'll say 1 squared plus, let's just call this x. So x squared is equal to 3 squared. So this would be 1, and this would be 9. So basically you have a 9 over here, then minus 1, so that becomes 8. And then basically you have x squared equals 8. So because you're in quadrant 1, you want the principal square root. So x equals the principal square root of 8. Again, 8 is 4 times 2. So let's say the square root of 4 times the square root of 2. And of course, this is 2 here. So x equals 2 times square root of 2. So that's where we're getting that from. So let's go back up. And let's say that this right here is going to be 2 times square root of 2 over 3. So let me erase this and put 2 times square root of 2 over 3. Now, I wouldn't cancel anything here because 2 times 3 here and 2 times 3 here is going to give you a common denominator. So if you cancel those 2's there, you could write it like that if you want, but I'm going to keep it with a common denominator. So again, I'm just going to say this equals 2 times square root of 2 minus the square root of 3 over the common denominator of 6. So let me go ahead and grab this. So I'm just going to look through my choices. Looks like it's this one. So 2 times square root of 2 minus the square root of 3 over 6. So that's the one that I want. All right, let's take a look at question 7 now. So we're asked to write each expression as an algebraic expression in U. And this is going to be for U is greater than 0. So what we have is the cosecant of the inverse cotangent of this square root of 4 minus u squared. And then this is over u. So let me close this down. Let me grab this real quick. And I'm going to go through all these little hints one by one. So let me just come to a fresh sheet here. And let's first start by thinking about, well, how does the inverse cotangent function work? Well, here's the graph. And again, this can be derived in a different way. But typically you see this as y equals the inverse cotangent of x. And so what I want you to realize is that if I plug in something for x here that's 0 or some positive value, then basically I'm going to get something in quadrant 1. So here's an x value of 0. That right there is going to be pi over 2, which of course is a quadrantal angle. And then anything that's greater than 0, you're going to get something that's in quadrant 1. Well, specifically here, we said that u is greater than 0. So that tells me that this guy right here, the square root of 4 minus u squared over u, well, if u is greater than 0, this guy right here, the range is going to be from 0 to positive infinity. And you can see that from this little graph here. So I gave you that on Desmos if you want to look at it. So y equals the square root of 4 minus x squared over x, where x is greater than 0. The range for this guy, or what's going to come out of it, is going to be from 0, and including 0, going out to positive infinity. So if we think about this, coming back here, I know that the argument here is going to be non-negative, so the inverse cotangent of something that's non-negative, I'm going to go ahead and sketch that in quadrant 1. I realize that if you plug in 0, you get pi over 2, which is quadrantal, but let's just say we're going to sketch our triangle in quadrant 1. So let's say that we're going to let something like theta be equal to the inverse cotangent of the square root of 4 minus u squared over u. I'm going to state that theta is in quadrant 1 for what we're going to do here. And then I'll also say, then the cotangent of theta is equal to the square root of 4 minus u squared over u. So really the problem turns into the cosecant of theta. I'm just going to write that on a new sheet. So the cosecant of theta is equal to, again, this is going to be the hypotenuse over the opposite. So it's the reciprocal of the sine function. All right, so let's see if we can figure out what is the opposite and the hypotenuse. From the cotangent of theta, I know that this is going to be the adjacent over the opposite. So I know the opposite is u. That sort of looks like a 4, so let me rewrite that. That is a u. Let me come down here. I know that the opposite is going to be u. So how do I get the hypotenuse? Again, you could sketch a triangle. So the opposite is u. The adjacent is the square root of 4 minus u squared. So the hypotenuse is actually going to be 2. So let's go ahead and show this real quick. If I have the square root of 4 minus u squared, and this would be squared, and then plus if I have this u squared, this is equal to this guy right here, which at this point it would be unknown. Let's just call it r. So r squared. Okay, so this guy being squared, you can get rid of this. And then this guy being squared, you leave that alone. But you have negative u squared plus u squared. That's going to go away. So you have r squared is equal to 4. So you want the principal square root of 4, which is 2. So you can say r, or the hypotenuse here, is 2. So coming back, this hypotenuse here is going to be 2. So the cosecant of theta, which is what we're trying to find, is going to be 2 over u. So coming back, I want to answer this as 2 over u. All right, let's take a look at question 8 now. So we're asked to find all solutions in radians, and we're told here that n is any integer. So we have negative 3 minus 3 cotangent of theta is equal to negative 2 minus 4 cotangent of theta. So your goal here is to isolate the cotangent of theta. So the cotangent of theta equals some number, and then you can use the unit circle, although the cotangent values are not on the unit circle, but you can use the unit circle to think about things. So what I'm going to do here is first add 4 cotangent of theta to both sides of my equation. So that's going to cancel away. And let me add 3 to both sides of the equation. So that's going to cancel away. Negative 3 cotangent of theta plus 4 cotangent of theta, that's going to be the cotangent of theta, and this equals negative 2 plus 3, that's going to be positive 1. Okay, so most of you know this without going to the unit circle or thinking about any special triangles. The cotangent of theta is going to be equal to 1 at pi over 4 plus pi n, where n is any integer. Again, although the cotangent values aren't on the unit circle, you can just use it to think about things. So here's pi over 4, and we know that for the cotangent of pi over 4, it's the cosine of pi over 4 divided by the sine of pi over 4, which is going to be equal to 1. The cosine value and the sine value are the same. Now, when you have a period of pi, that means that if I swing around by pi and I go into quadrant 3, where I have a pi over 4 reference angle, that 5 pi over 4 guy right there, well, now I have the same cosine and sine value again, so the cotangent of 5 pi over 4 is going to be 1 as well. So this would keep happening forever and ever and ever. So you could start with pi over 4 and say plus pi n, where n is any integer. You'll keep getting solutions over and over and over. So let's come back up and say that we want pi over 4 plus pi n, where n is any integer. All right, let's take a look at question 9. So again, we're asked to find all solutions in radians, and we're told that n is any integer. So we have negative 1 plus 7 tangent of theta is equal to 3 plus 3 tangent of theta. So the idea here is that, again, you want to isolate the tangent of theta on one side and have a number on the other. So I'm going to subtract 3 tangent of theta away from each side of the equation. So this would cancel. And then let me add 1 to both sides of the equation. So that cancels. 7 tangent of theta minus 3 tangent of theta, that's going to be 4 tangent of theta. And this equals 3 plus 1 is going to be 4. Let's divide both sides of the equation by 4. So this cancels. And you're going to say that this is going to be 1. So you're going to get that the tangent of theta is 1. So just like in the last problem, where we talked about the cotangent of theta being equal to 1, you're going to have pi over 4 plus pi n, where n is any integer. Let me write out that the tangent of theta is equal to 1. And again, if you want, you can think about this with the unit circle. So the tangent of, let's just say something like pi over 4. Well, this is the sine of pi over 4 divided by the cosine of pi over 4. And again, the sine and the cosine value, it's the same in this case. So this is going to be 1. And again, the period for tangent or cotangent is pi. So you have one there, then you're going to have another solution, again in quadrant 3, where your cosine and sine values are the same again. So the tangent of 5 pi over 4 would also be 1. And then again, if you keep adding pi, you're going to get to additional solutions. So coming back up, we want to say that it's pi over 4 plus pi n, where n is any integer. All right, let's take a look at question 10. So we're asked to find all solutions in radians, and we're also told that n is going to be any integer. So here we have the negative of the square root of 2 secant of theta plus 3 secant of theta equals the secant of theta cosecant of theta plus 3 secant of theta. So if I look at this immediately, I see that 3 secant of theta is on this side and 3 secant of theta is on this side. So you can just mark it off from each side. For the sake of the tutorial, let me fully show what's going on. So I'm just going to subtract 3 secant of theta away from each side of the equation. So this would cancel and this would cancel. Of course, if you're doing this on your own, you could just mark it out and be done with it. Now, what you're going to have is the negative of the square root of 2, and then secant of theta is equal to the secant of theta cosecant of theta. Now, the common mistake when you're solving a trigonometric equation is to divide both sides by a trigonometric function. So you don't want to divide both sides by the secant of theta. Again, in some cases, not in every case, but in some cases, you could remove some of your solutions. Doesn't always happen, but instead of doing that, what you want to do is move this over here and then factor. So I'm just going to subtract the secant of theta, cosecant of theta, away from each side of the equation. And so that's completely legal. And basically, this would cancel and give me 0. And so now we're going to have the negative of the square root of 2, and then secant of theta minus the secant of theta cosecant of theta, and this equals 0. Let me slide down here for a moment. And basically, we're thinking about, we have the secant of theta and the secant of theta, so that's common. So basically, you can just pull that out in front of some parentheses and say you have the secant of theta times the quantity. You'd have the negative of the square root of 2, and then minus. Here you'd have the cosecant of theta. Let me make this s a little bit better there. Close that down, and this equals 0. So at this point, I can use my zero product property. Let me slide down a little bit. And you're going to first say the secant of theta equals 0. So the secant of theta is equal to 0. Now, most of you know this has no solution. So let me go ahead and arrow to this and say this has no solution. Now, if you think about why it has no solution, again, we've seen the graph of y equals the secant of x many times. Basically, you're plugging in a 0 for y, and you're saying, for which x value am I getting a y value of 0, or where are the x-intercepts? Well, you don't have any. So basically, there's no x value there that will give you a y value of 0, so there's no solution. Okay, so coming back, let me put or. Now you're going to deal with this guy inside of parentheses. So you have the negative of the square root of 2 minus the cosecant of theta is equal to 0. You can add the square root of 2 to both sides of the equation. That cancels. You're going to get the negative of the cosecant of theta is equal to the square root of 2. Let me get rid of this real quick and move this up here. And basically, I would just divide both sides by -1. And so this would cancel. And you get the cosecant of theta is equal to the negative of the square root of 2. So basically, you're just going to work on this right here. So let me write the cosecant of theta is equal to the negative of the square root of 2. So basically, I would convert this over into a problem that involves the sine of theta. So let's just say that the sine of theta is equal to 1 over the cosecant of theta. And the cosecant of theta is the negative of the square root of 2. So this would be 1 over the negative of the square root of 2. Let me actually get rid of this. If you rationalize the denominator, so times the square root of 2 over the square root of 2, you're going to say that the sine of theta is equal to the negative of the square root of 2 over 2. So this is the negative of the square root of 2 over 2. Okay, so this is pretty easy to solve. We know that the sine of pi over 4 is going to be square root of 2 over 2. So basically, where is sine negative? Well, it's going to be negative in quadrants 3 and 4. So I'm looking for a pi over 4 reference angle. So that's going to be right here at 5 pi over 4, and then right here at 7 pi over 4. And you can see that the sine value is negative square root of 2 over 2 here, and then also here. That's your sine value, negative square root of 2 over 2. So basically, you would take this solution of 5 pi over 4. So let's say theta is equal to 5 pi over 4. And then you're going to add 2 pi n, where n is any integer, because we're just working with the standard period for sine, and that's going to be 2 pi. And then basically, you would have 7 pi over 4, so this solution right here. And then again, this is going to repeat every 2 pi, so plus 2 pi n, where n is any integer. So let me come back up here and paste this in. So I'm looking for, looks like this one right here. I want 5 pi over 4 plus 2 pi n, and then 7 pi over 4 plus 2 pi n, where n is any integer. All right, let's take a look at question 11. So we're asked to find all solutions in radians. Again, we're told that n is going to be any integer. So we have 2 sine squared theta, and then plus 1 is equal to 3 sine of theta. Let me go ahead and grab this real quick and come to a little fresh sheet. When I see something that's squared in a problem like this, I'm thinking that it's quadratic in form. In most cases, you can factor and solve that way, but in some cases, you'll have to use the quadratic formula. Here, we're going to be able to factor, so I'm just going to subtract 3 sine of theta away from each side of the equation. That's going to cancel and give me 0. So I have 2 sine squared theta minus 3 sine of theta, and then plus 1 equals 0. Okay, so how are we going to factor this? You have 2 sine squared theta, so 2 is a prime number, so let's write 2 sine of theta, and then sine of theta. Now, 1 can only come from negative 1 times negative 1, or positive 1 times positive 1. Because this middle guy here is negative, this is going to have to be a negative 1 and a negative 1 here. So basically, your outer is negative 2 sine of theta, and your inner is negative sine of theta. If you add those together, negative 2 sine of theta plus negative sine of theta, that's negative 3 sine of theta. So this is the correct factorization. All right, let's take a look at the zero product property now. So you're going to take each factor and set it equal to 0 and solve that. So 2 sine of theta minus 1 equals 0. And then or you have the sine of theta minus 1 is equal to 0. So over here, let's add 1 to both sides of the equation. That cancels. You get 2 sine of theta. Let me make that n a little bit better there. This equals 1. Divide both sides by 2, and you're going to get sine of theta equals 1/2. So this right here is sine of theta equals 1/2. Let me move that up there. On this one, you just add 1 to both sides. So let's just say that sine of theta is equal to 1. If you go to the unit circle and you look for where the sine of theta is equal to 1/2, or the sine of theta is equal to 1, well, sine of theta is 1/2 at pi over 6. There's your sine value of 1/2. And then 5 pi over 6, again, there's your sine value of 1/2. Sine of theta equals 1 at pi over 2. So basically, again, your period for the sine function is 2 pi. So you would say that theta is equal to, let's go pi over 6 plus 2 pi n. And then let's go pi over 2 plus 2 pi n. And then let's go 5 pi over 6 plus 2 pi n, again, where n is any integer. So let's come back up and paste this in. So you're looking for this guy right here. So you want the pi over 6 plus 2 pi n, pi over 2 plus 2 pi n, and then you want 5 pi over 6 plus 2 pi n, where n is any integer. All right, let's take a look at question 12. So now we're asked to solve each for theta is greater than or equal to 0 and less than 2 pi. And we're given cosine of x times cosine of 3x equals sine of x times the sine of 3x. Now I have a hint here that says look over the identities handout. So you might have looked at that and said, how in the world do you get a solution? It's actually pretty easy. You're going to write this as the cosine of x times the cosine of 3x, and then minus the sine of x times the sine of 3x. Let me actually wrap this for consistency. Let me move this down here like this, and this would be equal to 0. So I just subtracted the sine of x times the sine of 3x away from each side of the equation. And once you do this, let me go ahead and cut this away. You can look over your identities handout, and what you're going to see is that this right here matches this right here. You basically have the cosine of a times the cosine of b minus the sine of a times the sine of b. So basically you're going to use this right here, and you're going to reverse this and go to this. So in other words, I can write this legally as the cosine of this first guy x plus this second guy 3x, and just say this equals 0. That's basically all I'm doing. And at this point, I can just combine like terms and say this is going to be the cosine of 4x is equal to 0. Now let's think about this using the unit circle. So if you have something like the cosine of 4x equals 0, again, I like to make a substitution. You don't have to, but I would let something like u be equal to 4x, and then I would just say, okay, the cosine of u equals 0. So u is equal to what? Well, where is the cosine value 0? Well, it's going to be right here at pi over 2, and then right here at 3 pi over 2. So you can basically say pi over 2 plus pi n, so pi over 2 plus pi n, where n is any integer. Okay, well, u is 4x. So let me back substitute here and say this is 4x, and I want to solve for x. So that would be me dividing everything by 4 or multiplying everything by a fourth. So x would be equal to pi over 2 times 1/4, so that's pi over 8, and then plus, you're going to have pi over 4 times n. Now, for what we're going to do, since we want to solve over an interval, you're going to convert this over into 2 pi over 8. You're just going to make it easier to work with. Let me grab this real quick and come up here and paste this in. So that would be the general solution. Again, normally you would put pi over 4 times n, where n is any integer. What I'm going to do is just start with the first solution, which would be pi over 8. Let me put x is equal to this. And then you're going to keep adding 2 pi over 8 to get to the next solution. Of course, you want to stop when you get outside of this interval. So basically, this is going to be 3 pi over 8, and then you're going to get 5 pi over 8, and then 7 pi over 8, and then 9 pi over 8. You'd have 11 pi over 8, and then 13 pi over 8, and then 15 pi over 8. Now that's where I'm going to stop, because if you do 17 pi over 8, that's not in the interval from 0 to 2 pi, where 0 is included and 2 pi is excluded. So this right here is the one that you want. You want your pi over 8, 3 pi over 8, 5 pi over 8, 7 pi over 8, 9 pi over 8, 11 pi over 8, 13 pi over 8, and finally 15 pi over 8. All right, let's take a look at question 13. So we're asked to solve each for theta is greater than or equal to 0 and less than 2 pi. So we have 3 minus the cotangent of theta is equal to the negative of the cosecant of theta plus 2. Remember, we have a little identity that is going to link both of those. So 1 plus cotangent squared theta equals cosecant squared theta. So what I can do is actually subtract 2 away from each side here. Let me cancel this away. And so I would have 3 minus 2, that's 1. So let's say 1 minus the cotangent of theta is equal to the negative of the cosecant of theta. All right, let me get rid of this. And what I'm going to do is square both sides. So I'm going to square this side, and I'm going to square this side. Now let me stop for a moment. Remember, when you square both sides of an equation, you introduce the possibility of extraneous solutions. So solutions that do not work in the original equation. So when you square both sides of an equation, you have to check all of your solutions. It's really important. So this right here, you would expand this. So it's the first guy squared. So 1 squared is 1. And then you have a minus 2 times this guy times this guy. So 2 cotangent of theta. And then plus the last guy squared. So cotangent squared theta. And this equals over here, the negative goes away, and you would just have cosecant squared theta. Okay, so now that we have this in this form here, you have cosecant squared theta, and you have cosecant squared theta. Those are a match. So since the cosecant squared theta equals 1 plus the cotangent squared theta, I can just plug this right here in for that right there. So let me circle this so it's crystal clear what I'm plugging in, not just the cotangent squared theta, but 1 plus that. Okay, so this is what I'm going to do. I'm going to have 1 minus 2 cotangent of theta plus cotangent squared theta is equal to, again, plug this in for this. So we're going to have 1 plus cotangent squared theta. Okay, let me get rid of this. Basically, at this point, you would notice that you have cotangent squared theta and cotangent squared theta. You can just subtract it away from each side of the equation. Of course, you could just cancel it away once you notice that, but just for completeness, I'll just go through the steps. So that's going to be gone, and basically you have a 1 and a 1. So let me subtract that away from each side of the equation. So that's gone. So basically, you just have negative 2 cotangent of theta is equal to 0. Okay, let me get rid of this. Now let's think about this. You can divide both sides by negative 2, and basically what you're going to get is the cotangent of theta is equal to 0. So where is the cotangent of theta equal to 0? Let's go to the unit circle, and let's think about this. So the cotangent of theta equals 0. Well, basically, when you think about the cotangent of theta, it's going to be your cosine of theta over your sine of theta. So if you want a value of 0, you need the numerator to be 0 and the denominator to be not 0. So where is cosine going to be 0? Well, it's going to be right here at pi over 2, and then right here at 3 pi over 2. And notice the sine value is not 0, so you're basically good to go. So theta would be pi over 2. You could say plus pi n, but since we're not dealing with a general solution, I'm just going to put 3 pi over 2. Now, it's not necessarily true that these are going to work as solutions, because again, we squared both sides of our equation, so we have to check. So I went ahead and just plugged in already. So 3 minus the cotangent of, I'm checking pi over 2, equals negative cosecant of pi over 2 plus 2. What is the cotangent of pi over 2? That's 0. So this would be 3 is equal to, what is the cosecant of pi over 2? Well, remember the sine of pi over 2 is 1, and the cosecant is basically the reciprocal of that, which is still 1. So this would be the negative of 1 plus 2. So negative 1 plus 2 is going to be positive 1. So this is 3 equals 1, which is a false statement. So this right here does not work. It's extraneous. So for the other one, let's go ahead and paste this in. You have 3 pi over 2 being plugged in now. So the cotangent of 3 pi over 2, again, that's 0. So you'd have 3 is equal to, what is the cosecant of 3 pi over 2? Again, the sine of 3 pi over 2 is negative 1. So you take the reciprocal of that, it's still negative 1. So you'd have the negative of negative 1 plus 2. The negative of negative 1 is positive 1. Be very careful when you're plugging in there. This right here is negative 1, and you have a negative out in front of that. So it becomes minus a negative, which is plus a positive. So it's positive 1. 1 plus 2 is 3. So you get 3 equals 3. So this solution is valid. So theta here is only 3 pi over 2. Again, make sure you check things when you square both sides of an equation. So coming back up, I just want 3 pi over 2 only. Again, not this one, but this one. Pi over 2 is an extraneous solution. All right, let's take a look at question 14. So we want to solve each for theta is greater than or equal to 0 and less than 2 pi. We have negative 2 cotangent of theta minus the cosecant of theta is equal to negative 2 cosecant of theta. So what I'm going to do to start this problem is just add the cosecant of theta to both sides of the equation. This cancels. You get negative 2 cotangent of theta is equal to, we're going to have negative cosecant of theta. Now, when I check things, I'm actually going to use this form. So you might want to write this down for later on. Let me go ahead and grab this real quick and come down here to a little identity that we can use. So you have 1 plus cotangent squared theta equals cosecant squared theta. What I'm going to do is square both sides here. And so essentially, if I square this, negative 2 squared is 4. And then you have cotangent of theta squared, so cotangent squared theta. And this equals, over here, negative 1, you could treat it like that. Negative 1 being squared is positive 1. So basically, you just have the cosecant squared theta. Okay, let me actually get rid of this. So using this identity, you can see that this matches this. So all we're going to do is we're going to take this right here, and we're going to plug it in for this right here. So you're going to have 4 cotangent squared theta is equal to, again, I'm plugging this in for this, so 1 plus cotangent squared theta. At this point, I would subtract cotangent squared theta away from each side of the equation. And so, of course, this is going to cancel. You're going to get 4 cotangent squared theta minus cotangent squared theta. That's going to be 3 cotangent squared theta, and this equals 1. At this point, I'm going to divide both sides of the equation by 3, and I'm going to get cotangent squared theta is equal to 1/3. Now, by the square root property, what we can do is say that the cotangent of theta is equal to plus or minus the square root of 1/3. So basically, this is the square root of 1 over the square root of 3. We know that the square root of 1 is 1, and then over the square root of 3, I would multiply this by the square root of 3 over the square root of 3 to rationalize the denominator, so you get plus or minus the square root of 3 over 3. So the square root of 3 over 3. So let's grab this real quick, and let's come to the unit circle. Again, you can't directly get the cotangent value from the unit circle, but you can use it to think about things. First off, a lot of you already know that the cotangent of pi over 3 is square root of 3 over 3. If you don't know that, again, you can just say the cotangent of pi over 3 is equal to the cosine of pi over 3, which is 1/2, divided by the sine of pi over 3, which is square root of 3 over 2. So I'm going to multiply by the reciprocal there. So times 2 over the square root of 3. The 2's cancel, and you get 1 over the square root of 3. Of course, if you rationalize the denominator there and multiply by square root of 3 over the square root of 3, you get the square root of 3 over 3. So I know that at pi over 3, or anywhere with a reference angle of pi over 3, I'm going to get a cotangent value that is square root of 3 over 3 or negative square root of 3 over 3. So this would be square root of 3 over 3, this would be negative square root of 3 over 3, this would be square root of 3 over 3, and then this would be negative square root of 3 over 3. Okay, let me get rid of this, and let me write that in. So basically, you're going to have theta is equal to pi over 3. You're going to have 2 pi over 3. You're going to have 4 pi over 3, and then 5 pi over 3. Now, before I move on, let me just write this, and you want to put this down for your notes because we're going to check things pretty quickly. So the cotangent of pi over 3, just write down that that's square root of 3 over 3. And of course, when you get into quadrant 2 or quadrant 4, this is going to be negative. If you're in quadrant 1 or quadrant 3, this is going to be positive. And I'm just talking about having a pi over 3 reference angle. Now, the other guy we're going to look at is the cosecant of, again, let's just use pi over 3 to start. So this is, again, 1 over the sine of pi over 3, and the sine of pi over 3 is square root of 3 over 2. So this would be 2 over the square root of 3. You would rationalize the denominator. So just keep in mind that this is 2 times square root of 3 over 3, and this is going to be also 2 times square root of 3 over 3 at 2 pi over 3. And then it's going to be negative 2 times square root of 3 over 3 at 4 pi over 3 and also at 5 pi over 3. So keep in mind where cosecant is negative in quadrants 3 and 4, and cotangent is negative in quadrants 2 and 4. Okay, let me go ahead and grab this real quick. Okay, let me come down here, and we're going to check things. Again, this is the alternative form of that equation. I just make it a little bit easier to work with. So if you plug in a pi over 3 here and a pi over 3 here, remember the cotangent of pi over 3 is square root of 3 over 3, and the cosecant of pi over 3 is 2 times square root of 3 over 3. So this would be negative 2 times square root of 3 over 3 is equal to, this would be a negative 2 times square root of 3 over 3. So yeah, this one does work. All right, let me come down to this other one here. So this one's actually not going to work. I'm just going to show it as rejecting. So you'd have negative 2 times the cotangent of 2 pi over 3. Again, this is going to be negative because we're in quadrant 2. So this is negative square root of 3 over 3. Is this equal to the negative of, again, the cosecant of 2 pi over 3. I'm in quadrant 2, so this is still positive. And this is going to be 2 times the square root of 3 over 3. So this negative is coming from this right here. Okay, so just keep that in mind. This value right here, the cosecant of 2 pi over 3, that is positive, but you have the negative that's applied to that. Over here, you have a negative 2 times this value here is a negative square root of 3 over 3. So what's going to happen is you're going to get a positive 2 times square root of 3 over 3, and over here, you're going to have a negative 2 times square root of 3 over 3. So this is going to be false. These are not going to work. Okay, so here it's not going to work again. And that's because this guy's now going to be positive and this guy's going to be negative. So you can go through and plug it in. I'll actually do it for completeness. You're going to have negative 2 times the cotangent of 4 pi over 3. Again, we're in quadrant 3, so this is positive. So this is times the square root of 3 over 3. And then this is equal to, here you have a negative, but then this is going to be negative. So it's going to be a negative of a negative, which is positive. The cosecant of 4 pi over 3, again, you're going to get negative 2 times square root of 3 over 3. Negative of a negative is positive. So again, this does not work, right? It's going to be false. Let me put that this is false, and we've already rejected it. All right, so the last one is to check 5 pi over 3, and that's going to work again. So if we do negative 2 times the cotangent of 5 pi over 3, so that's going to be negative square root of 3 over 3. Remember that cotangent is negative in quadrant 4. And is this equal to, you have the negative of, Here, the cosecant of 5 pi over 3, again, this is in quadrant 4 where cosecant is negative. So this is going to be negative 2 times the square root of 3 over 3. So negative of a negative is a positive. So let's just change that. And then here, negative 2 times negative square root of 3 over 3, that's going to be positive 2 times square root of 3 over 3. So these two sides are the same. So this guy does work, this 5 pi over 3. So coming back up, this is what you want. You want pi over 3 and 5 pi over 3 only. All right, let's take a look at question 15 now. So we want to solve each for theta is greater than or equal to 0 and less than 2 pi. And we have the negative of the sine of theta minus the square root of 3 cosine of theta minus the cosine of theta is equal to negative cosine of theta. So all I'm going to do is clean this up because we're going to have to check this as well. So I'm going to get rid of some stuff here. So I'm just going to add the cosine of theta to both sides of the equation. So that cancels, and this gives me 0 over here. What I would do at this point is add the square root of 3 cosine of theta to both sides. So let me show that over here. So at the end of the day, I'm going to cancel this away and say that we're going to work with negative sine of theta is equal to the square root of 3 cosine of theta. A lot of you know the identity sine squared theta plus cosine squared theta equals 1. This is just a different form of that. And basically to use it, we're just going to square both sides. So I'm going to square this side and I'm going to square this side. Again, if you square both sides, you have to check your solutions. So the negative goes away. This is sine squared theta. This equals the square root of 3 squared is 3. And then this is cosine squared theta. Okay, at this point, again, you're just looking for the fact that this is going to match this. And so you're going to plug this right here, this 1 minus cosine squared theta, in for this right here. So you're going to have 1 minus cosine squared theta is equal to 3 cosine squared theta. Let me get rid of this. We don't need it anymore. And basically, all you have to do here is add cosine squared theta to both sides of the equation. So that cancels. And let me write this over here. I like what I'm solving for on the left. So we'll say we have 4 cosine squared theta is equal to 1. Go ahead and divide both sides of the equation by 4. That cancels. You're going to get cosine squared theta is equal to 1/4. So basically at this point, you're going to use your square root property. And we're going to say that the cosine of theta is equal to plus or minus the square root of 1/4, which we know is 1/2. Now, most of you know that the cosine of pi over 3 is going to be 1/2. But again, you can come to the unit circle and see that. Here's pi over 3, your cosine value is 1/2. And then in terms of where is it either positive 1/2 or negative 1/2, well, that's anywhere where you have a reference angle that's pi over 3. So you have negative 1/2 there at 2 pi over 3, and then you have negative 1/2 there at 4 pi over 3, and then you have positive 1/2 there at 5 pi over 3. So basically, let's write that theta is equal to pi over 3. Let's put 2 pi over 3. Let's put 4 pi over 3, and then let's put 5 pi over 3. Okay, let's grab this real quick. All right, let's go ahead and check this. It's pretty easy overall. You know that the sine of pi over 3 is square root of 3 over 2, and the cosine of pi over 3 is 1/2. We just need to think about when we get to the other ones, based on the quadrant we're in, is it going to be positive or negative? For this one, it's going to be the negative of, again, this is the square root of 3 over 2. Here you have the square root of 3 times, this is positive 1/2, so square root of 3 over 2. This is a false statement, right? So those are not equal, so you can mark that one out. Okay, for the next one, we know that the sine of 2 pi over 3, I'm in quadrant 2, so it's still square root of 3 over 2. But this is a negative out in front, so this is negative square root of 3 over 2. And this equals, cosine is negative in quadrant 2, so this would be negative 1/2 times square root of 3, so that's negative square root of 3 over 2. So this one does work. Let's come down here. Let's check this one. So the sine of 4 pi over 3, again, now you're going to be in quadrant 3, so this guy is negative. So you have a negative of a negative. Let me write that out. So negative, and this would be negative square root of 3 over 2. And this equals, over here, 4 pi over 3 again is in quadrant 3. So the cosine of something in quadrant 3 is going to be negative. So this would be negative 1/2 times the square root of 3. So this is the negative of the square root of 3 over 2. This minus a negative becomes plus a positive. So basically this is false, right? You have a positive is equal to a negative. So that's never true. So this is false. So 4 pi over 3 is rejected. Coming to the last one, which is 5 pi over 3, you're going to see this works again. So you have the negative of, again, this sine of 5 pi over 3, you're in quadrant 4, so it's going to be negative. So negative square root of 3 over 2, this equals We're in quadrant 4, so cosine's positive. The cosine of 5 pi over 3 is a half. A half times square root of 3 is the square root of 3 over 2. But this is minus a negative, so it becomes a positive. And so again, it works. So the only valid solutions here are 2 pi over 3 and 5 pi over 3. So coming back up, I want this one right here. So 2 pi over 3 and 5 pi over 3. If you selected this one, it's not correct, because when you look at pi over 3 and when you look at 4 pi over 3, those are extraneous solutions. They do not work in the original equation. All right, let's take a look at question 16. So now we have 4 to the power of sine squared x, so this is an exponent, plus 4 to the power of cosine squared x, so again, this is an exponent, and this equals 5. Let me just write this real quick. So 4 to the power of sine squared x, and then plus 4 to the power of cosine squared x, and this equals 5. So when you first see this problem, you might be thinking, how in the world are we going to solve that? We've never seen anything like that. But if you follow the little hints that I gave you, it's not that bad. So the first thing is to think about how you can replace cosine squared x using identities. So remember that sine squared x plus cosine squared x is 1. And then think about the rule. This one's going to come up in a moment. So x to the power of a minus b is x to the power of a over x to the power of b. And then we're going to basically make a substitution. And from that point on, it's going to be very, very simple. So let's come down here where I have a little identity set up so we can get going. So the first thing is I'm just going to take this right here and match it up with this right here. So you're going to plug this right here, this 1 minus sine squared x, in for that right there. So all you're going to have is 4 to the power of sine squared x plus 4 to the power of, now it's going to be 1 minus sine squared x, and this equals 5. And let's go to that next hint. So basically at this point, you want to use your quotient rule for exponents to break this up. So if I had something like, let's say, 4 to the power of 1 over 4 to the power of sine squared x, well, using this rule here, the base stays the same, so it's just going to be 4, and then you're going to subtract the exponent in the numerator, which is 1, minus the exponent in the denominator, which is sine squared x. Okay, so because we can go from this to this, we can go back from this to this. So all I'm going to do, let me slide down a little bit. It's going to go off the screen, but hopefully you can remember it. I'm going to say this is 4 to the power of sine squared x plus, again, this is going to be 4 to the first power. You could just write 4 if you want. Over, you're going to have that 4 to the power of sine squared x. Again, I can legally go from this form to this form, and so I can go back from this form to this form. Now I'm going to erase this 1 here. We don't need it. And this equals 5. Now at this point, here's where you want to make a substitution. So I'm going to let something like, normally I use u, but since there's a 4 in the problem, that's going to get mixed up. So I'm just going to use w be equal to the 4 to the power of sine squared x. So that's going to really make the problem simple. Let me come down here, and let's say that we have w plus 4 over w is equal to 5. So again, I just plugged in, let me make this 4 a little bit better here. I just plugged in a w for this guy and this guy. That's all I did. Now, if you want to solve this, just multiply both sides by w. So multiply this by w, multiply, let me slide this down so I can fit this. So multiply this by w and multiply this by w. So w times w is w squared. These w's would cancel, so plus 4, and this equals 5w. So this guy's going to be a quadratic. Let me subtract 5w away from each side. So let me show that like this. This would cancel and give me 0. So now you're going to have w squared and then minus 5w, and then plus 4 is equal to 0. Maybe the w's could be a little bit better there. So let me try to make that better and make that better. This is something you could factor. Let me go ahead and grab this. So you can factor this. It's really easy to factor. So basically, this is a w and this is a w. Give me two integers whose sum is -5 and whose product is +4. That's going to be -4 and -1. So -4 plus -1 is -5. -4 times -1 is +4. So then you get w minus 4 is equal to 0, or w minus 1 is equal to 0. So add 4 to both sides there, you get w is equal to 4, or add 1 to both sides, you get w is equal to 1. Okay, let's go ahead and grab this real quick. So come back to this point. Remember that we let w be equal to 4 to the power of sine squared x. So you're going to have to say that 4 to the power of sine squared x, and that n is not so good. So let me make that a little bit better. So again, this is going to be equal to 4. if this is confusing, again, w is this, right? So all I'm doing is I'm saying, well, if w is this, here's a w, so I can just replace it with 4 to the power of sine squared x, and that just equals 4. Then I'm going to do that again. So I'm going to say, or you're going to have 4 to the power of sine squared x, again, that's w, is equal to 1. So now we have something that we can solve pretty easily. So the first one's very simple. Again, if you have like bases here, you have a 4 and you have a 4, what you're going to do is set the exponents equal to each other. So you're just going to say sine squared x is equal to 1. So by the square root property, this is sine of x is equal to plus or minus 1. So we'll solve that in a moment. Let me get rid of this and slide this over. And basically, let's go or. Over here, you might be thinking about, do I need a logarithm or something like that? Remember that you can use a little trick here and say this is 4 to the power of 0. 4 to the power of 0 is 1. So that is completely legal. And now you have a 4 and you have a 4. So the bases are the same. So you just set the exponents equal. So you can say sine squared x is equal to 0. So now you can just say the sine of x is equal to 0. Okay, let me get rid of this. And actually, let me stack this up. Let me put or the sine of x is equal to 0. Let's come to the unit circle. I know most of you know this, but essentially let's go through it. Again, we're just working that interval from 0 to 2 pi where 0 is included and 2 pi is excluded. So here you're going to say that x is equal to, if I think about where the sine of x is 0, well, that's going to be right here at 0 and then right here at pi. Again, don't use 2 pi because that's not in the interval. So let's say that we have 0 and then we're going to have pi. Now, additionally, we're going to have sine of x equals plus or minus 1. So that's going to be right here at pi over 2 and then right here at 3 pi over 2. Okay, so coming down, we're going to say that we also have pi over 2 and then 3 pi over 2. So essentially, if you look at these solutions, you could say that it's going to be every pi over 2. So the general solution here would be pi over 2 times n, where n is an integer. So you'd have 0, pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2, so on and so forth. If you want to look at the graph of this guy, again, I left a link for you on Desmos, but you'll see that by manipulating the equation, I just subtracted 5 away from each side. If this was 0 over here for y, well, I'm looking for the x value that gives me a y value of 0, so I'm looking for the x-intercepts. So again, you see you get 0, pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2, 4 pi, 9 pi over 2, so on and so forth. So solutions are happening every pi over 2. So coming back up, you're going to want this answer right here. So 0, pi over 2, pi, and then 3 pi over 2. For this one, if you wanted to give a general solution, again, you could say pi over 2 times n, where n is any integer. All right, let's take a look at question 17 now. So we want to solve each for theta being greater than or equal to 0 and less than 2 pi. And what we have is the cosine of theta is equal to, we have 3 sine of theta over 2, and then plus 2. Okay, let's grab this real quick, and let's come down here. So you'll notice that I have 2 different identities set up, and you can solve this using different strategies. Typically, if you're using the textbook method, you're going to see that you have sine of theta over 2, and sine of theta over 2, you're going to use a little half angle formula. You're basically going to plug this in, square both sides, and solve it that way. The problem is when you square both sides of an equation, you introduce the possibility of extraneous solutions. And so because you have to go through and check things, it just makes it really, really tedious. So I'm not going to use that method here. I'm going to get rid of this, and I'm going to go back to what we used in the practice test. I just think this is so much easier that if you learn to use it and master it, it's going to make your life a lot better. So basically, I'm going to let something like u be equal to theta over 2. So theta over 2. And then if we multiply both sides by 2, you can say 2u is equal to theta. Okay, well, I have cosine of theta. Theta is 2u, so cosine of 2u is equal to 3 times the sine of theta over 2 is going to be u, and then plus 2. Okay, I'm just going to get rid of this for right now. We'll come back to this in a little while. I'm just going to move this up here, and I'm going to use this little double angle formula. Remember, the cosine of 2u, those match. So basically, I can say that I have 1 minus 2 sine squared u. That's going to get plugged in right there. So we're going to say 1 minus 2 sine squared u is equal to 3 sine of u plus 2. Just come to a fresh sheet here. We'll go back to that in a little while. For right now, let's just solve this and say that we have the sine of u equals some number, and we'll figure out what's going on. All right, so because this guy is quadratic in form, I'm just going to subtract 3 sine of u away from each side of the equation. And I'm going to subtract 2 away from each side of the equation. Let me just move this down here. I don't really have somewhere to put it, so let me just put minus 2 here. So basically, this is going to cancel and this is going to cancel. So this is 0 on the right. And so on the left, let me write negative 2 sine squared u. And then I have negative 3 sine of u. And then 1 minus 2 is negative 1. So minus 1 equals 0. And the first thing I would do here, if I'm trying to solve this with factoring, I would make this leading guy positive. So multiply everything by negative 1. So that's going to be positive, 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 and no change to 0. And now it's pretty easy to factor this guy. So basically, if you have a 2 here, that's a prime number. So this is 2 sine of u, and then sine of u. And then if this guy's a 1, and this guy's positive, well, that's only coming from 1 times 1. So I'm going to say plus 1 and plus 1. The other possibility is negative 1 times negative 1, but you have a positive guy there, so that's not going to work. So this right here, if you check it, this is 2 sine of u, and this right here would be the sine of u. So 2 sine of u plus sine of u, that's going to be 3 sine of u. So basically, we're good to go. So let's go ahead and solve this now. We have 2 sine of u plus 1 equals 0. All right, at this point, I'm just going to subtract 1 away from each side. That cancels. You're going to get 2 sine of u is equal to negative 1. Let me divide both sides of the equation by 2. This right here is going to cancel. We get the sine of u is equal to negative 1/2. Over here, I'm just going to say or. We have the sine of u plus 1 is equal to 0. Let me actually erase this and drag that stuff back up there. So this, I'll just bring this up here. And basically for this one, you just subtract 1 away from each side. And we'll say that the sine of u is equal to negative 1. Let me actually write it more compactly. So I'm going to say or the sine of u is equal to negative 1. So let me grab this real quick, come down here and paste this in. So where is the sine value negative 1/2? Well, that's going to be right here at 7 pi over 6. So at 7 pi over 6. And then also, you're going to have that right here. So at 11 pi over 6. Then when is the sine value negative 1? Well, that's going to be at 3 pi over 2. You see that your sine value is negative 1. So let me go ahead and write that u is equal to, I'm going to put 7 pi over 6, and I'm going to go plus 2 pi n, where n is any integer. And then I'm going to go 3 pi, so 3 pi over 2, plus 2 pi n, where n is any integer. And then 11 pi over 6 plus, let me slide this down so it actually fits. So 2 pi n, where n is any integer. You know that u is equal to theta over 2, so you're just going to erase this and put theta over 2. So essentially, if you want theta, you're going to multiply everything by 2. So 7 pi over 6 times 2 is 7 pi over 3, and then plus 2 pi n times 2 is 4 pi n. Then we're going to go 3 pi over 2 times 2, that's going to be 3 pi, and then plus 2 pi n times 2 is 4 pi n. 11 pi over 6 times 2 is 11 pi over 3, and then plus 2 pi n times 2 is 4 pi n. So this right here would be your general solution. And looking at it, if I'm thinking about theta is greater than or equal to 0 and less than 2 pi, I don't actually have a solution. So in this interval, there is no solution, because if I look at the solutions, you have 7 pi over 3, which is greater than 2 pi. You have 3 pi, which is obviously greater than 2 pi. And then 11 pi over 3, which is greater than 2 pi. So again, in this interval, you don't have a solution. This right here would be your general solution. So if you wanted to list that, if you got this question on a test and then said, hey, what's the general solution? You could list this. But if they restricted it to this interval where theta is greater than or equal to 0 and less than 2 pi, well, then you don't have a solution. So coming back up, I'm just going to select no solution, specifically here because of this interval that we said to solve it. So solve each for theta is greater than or equal to 0 and less than 2 pi. In that case, there's no solution. All right, let's take a look at question 18. So we want to solve each for theta is greater than or equal to 0 and less than 2 pi. So for this one, I'm going to immediately make a substitution. I'm going to let u be equal to this guy right here. So negative theta plus 5 pi over 6. And so I'm going to write this as 4 times the square root of 3, and then minus 1, plus you have 3 times the tangent of, this would be u, and then this equals negative 1 minus 9 times the tangent of, again, this is u. Now you have negative 1 here and negative 1 here, so you can add 1 to each side of the equation. get rid of this, and get rid of this. I'm just going to erase it and make this a little bit easier to understand. And once you do this, it's a very, very easy problem to solve. So essentially, you want the tangent of u equals some number. Let me add 9 tangent of u to each side, like this. So that cancels, and you get 0. And let me subtract 4 times square root of 3 away from each side. So that cancels. So essentially, you get 3 tangent of u plus 9 tangent of u. That's going to be 12 tangent of u. So let me write here that we have 12 tangent of u. And this would be equal to, over here you have negative 4 times square root of 3. So negative 4 times the square root of 3. Let's divide both sides of the equation by 12. And so this right here is going to cancel, and you get the tangent of u is equal to, this would be 4 divided by 4 is 1, 12 divided by 4 is 3. So negative square root of 3 over 3. So coming to the unit circle, let's just think about where is the tangent value. Forget about the fact that this is negative. Just think about square root of 3 over 3. So the tangent of pi over 6 is equal to the sine of pi over 6, which is 1/2, divided by the cosine of pi over 6, which is square root of 3 over 2. So I'm going to multiply by the reciprocal, so times 2 over the square root of 3. This cancels. You get 1 over the square root of 3. If you rationalize the denominator, you get the square root of 3 over 3. So that means in quadrant 2 or quadrant 4, where I have a reference angle of pi over 6, I'm going to have a tangent value of negative square root of 3 over 3. So that's going to be here at 5 pi over 6, and then here at 11 pi over 6. Now, what you can do is list your solution as u is equal to 5 pi over 6 plus pi n, where n is any integer. The period for tangent, and this is just tangent of u here that we're working with, is just going to be pi. So basically, I get a solution, I add pi, and I get to another solution, I add pi, and I get to another solution, so on and so forth. So let's just grab this real quick and come back up here. And basically, since u is equal to this, you're just going to plug in a negative theta plus 5 pi over 6 in for u. You can get rid of this, and now you just solve this for theta. The first thing I would do is subtract 5 pi over 6 away from each side of the equation. So essentially, this is going to cancel and this is going to cancel. So you get negative theta is equal to pi n, where n is any integer. So basically what you could do is divide both sides by -1 or multiply both sides by -1, and you're going to get that theta is equal to negative pi n. Now, because n is any integer, you can actually get rid of the negative here and just leave it as pi n, just a simpler form. So basically, theta equals pi n. Okay, so we're in this interval where theta is greater than or equal to 0 and less than 2 pi. So what I would want to do is plug in a 0 for n, and that would give me 0. So one solution is theta is equal to 0. Then if I plugged in a 1, I would get pi. If I plugged in a 2, I would get 2 pi, but that's not in this interval. So basically, in this interval, the solutions are 0 and pi only. So that's what I want right there. All right, let's take a look at question 19 now. So we want to solve each for theta is greater than or equal to 0 and less than 2 pi. And what we have here is the sine of 2 theta plus the square root of 2, and then sine of theta equals 0. Come down here and paste this in. Now, basically, for the sine of 2 theta, you just have one identity that you can use. So this is going to match this, and you're just going to take this right here and plug it in for this right here. So you're going to have 2 sine of theta and then cosine of theta plus the square root of 2 sine of theta is equal to 0. Basically, at this point, I would factor out the sine of theta. So you have it there and there, so it's common. So just pull that out in front of some parentheses. We're going to have the sine of theta times the quantity 2 cosine of theta plus the square root of 2, and this equals 0. All right, so using the zero products property, we're going to say the sine of theta equals 0, and then or 2 cosine of theta plus the square root of 2 is equal to 0. So subtract the square root of 2 away from each side of the equation. This cancels. Let me just rewrite this as 2 cosine of theta is equal to the negative of the square root of 2. Divide both sides by 2. And essentially you get cosine of theta equals the negative of the square root of 2 over 2. And essentially if the sine of theta is 0, well, that's going to be right here at 0. and then right here at pi. And then for the cosine of theta to be the negative of the square root of 2 over 2, well, that's going to be right here at 5 pi over 4, and then that's also going to be right here at 3 pi over 4. So let me put that theta is going to be equal to, we have 0, we have 3 pi over 4, we have pi, and then we're going to have 5 pi over 4. So let me grab this real quick, and let me bring this back up. So I'm looking for this one right here. So we want 0, 3 pi over 4, pi, and then 5 pi over 4. All right, let's take a look at question 20. So here we want to solve each for theta is greater than or equal to 0 and less than 2 pi. And what we have is the sine of 5x minus the sine of 3x is equal to the cosine of 4x. Come down here and paste this in. So I have a little identity that we're going to use. So essentially, if you have sine of 5x minus the sine of 3x, you can use the sine of a minus the sine of b is going to be equal to 2 times the cosine of a plus b over 2 times the sine of a minus b over 2. So here a would be 5x and b would be 3x. And essentially you would say that this part right here is going to be 2 times the cosine of, you have a plus b over 2. So 5x plus 3x, that's 8x over 2, that's 4x. And then times the sine of, you have a minus b over 2. So again, 5x minus 3x, that's going to be 2x. 2x over 2 is x. And so now you just say this equals the cosine of 4x. Okay, so at this point, I'm going to subtract the cosine of 4x away from each side of the equation. That's going to cancel and give me 0. And this is something we're just going to factor. So you're going to have 2 cosine of 4x and then sine of x, and then minus cosine of 4x. So this equals 0. Now what you have here that's common is the cosine of 4x. So just pull that out. Don't worry about anything else at this point. So you have the cosine of 4x, and then inside the parentheses you'd have 2 sine of x. And then here, if I pull this out, it's a 1. You can put times 1 if you want to make that crystal clear. And that's a multiplication symbol. So let me make that crystal clear there. And so this would be minus 1 here. Close that down and say this equals 0. And let's say that you have the cosine of 4x, and you don't need parentheses here, I'll just take them away, is equal to 0. And then, or you have 2 sine of x minus 1 is equal to 0. For this one, I would add 1 to both sides. So this would be equal to 1, and then divide both sides by 2. So this one is the sine of x equals 1/2. So for the sine of x equals 1/2, let's just start with that one. That's going to be at pi over 6, and then 5 pi over 6. We're not finding the general solution, so you can just list that. So let's say this is x is equal to, let's go pi over 6, and then 5 pi over 6. Now this one is a little bit tricky. So you have cosine of 4x equals 0. Okay, so a lot of people will solve that without substitution. What I like to do is say I'm going to let u be equal to 4x, and then find the cosine of u equals 0. And so we know that that's going to happen. Let me actually erase this right here, so we're dealing with something else. So here at pi over 2, and here at 3 pi over 2. So what I'm going to say is that it's pi over 2. So I'm going to say it's pi over 2 plus pi n. So let's just go ahead and say that u is equal to pi over 2 plus pi n. Now remember, u is equal to 4x, so just plug in a 4x there, and then just divide everything by 4, or you can multiply everything by a fourth. So x is going to be equal to pi over 8. If I multiply that by a fourth, plus you'd have pi over 4 times n. I would write this as 2 pi over 8 times n, and that'll make it a little bit easier to go through and get your solutions. So let me move this out of the way, and we can just list the solutions. So let me put pi over 8, and then I'm just going to keep adding 2 pi over 8. So that's going to be going to 3 pi over 8, and then you would get 5 pi over 8, and then 7 pi over 8, and then 9 pi over 8, and then you would have 11 pi over 8, and then 13 pi over 8, and then 15 pi over 8, and that's where you're going to stop. If you go to 17 pi over 8, that's greater than 2 pi. So looking at my choices, it looks like I'm going to want this one right here. So it's not in the same order, but essentially if you look at this part right here, so you have pi over 8, 3 pi over 8, 5 pi over 8, 7 pi over 8, 9 pi over 8, 11 pi over 8, 13 pi over 8, 15 pi over 8, and then basically you have your pi over 6, which is this one, and then 5 pi over 6. These two came from solving sine of x is equal to 1/2, And then these all came from that cosine of 4x equals 0. So this is the solution you want. All right, let's take a look at question 21. So we want to solve each equation for the exact value. So we have the inverse sine of x is equal to the inverse tangent of 3/4. So for this type of problem, let me first just cut this away and come to a fresh sheet. I like to make a substitution. So I'll take what's known here, so the inverse tangent of 3/4. So I know what the ratio is here. So I'm just going to let something like theta be equal to this. So this is going to be an angle in quadrant 1. And I know that because the argument here for the inverse tangent function is positive. So I'm just going to say theta is in quadrant 1. And also you can say that the tangent of theta is 3/4. So this 3 right here is your opposite, and this 4 right here is the adjacent. So obviously the hypotenuse is 5. This is a 3, 4, 5 right triangle. Essentially what you're doing here is you're saying the inverse sine of x is equal to theta. Let me write that out. So the inverse sine of x is equal to theta. So this same theta here. And you could take the sine of each side if you want, or you can use the definition of the inverse sine function and just say if the inverse sine of x equals theta, then basically x is equal to the sine of theta. And the sine of theta, so the sine of theta is the opposite over the hypotenuse, and the opposite is going to be 3, and obviously the hypotenuse is 5. Again, it's a 3, 4, 5 right triangle. If you want to look at a sketch, again, this is your opposite, which is 3. Your adjacent is 4, so the hypotenuse is 5. Again, it's just 3 squared plus 4 squared. That's what we know, equals r squared. We've done this a million times, so this is 9 plus 16 is 25. So r squared equals 25. And so basically r equals the principal square root of 25, which is 5. So that's how you get this here. So coming back, the sine of theta is 3/5, and x is equal to the sine of theta. So that is 3/5. So that tells me the inverse tangent of 3/4 is equal to the inverse sine of 3/5. In other words, it's the same angle or the same theta. Here, the sine value is 3/5, so opposite over hypotenuse, and the tangent value is 3/4, so opposite over adjacent. So it's the same angle we're talking about in each case, this theta in quadrant 1. So coming back up, this x is going to be 3/5. All right, let's take a look at question 22. So here we want to solve each equation for the exact value. We have the negative of the inverse cosine of x is equal to the inverse sine of negative 15/17. So if I think about this problem, it can seem to be a bit tricky because right here, you have a negative argument for your inverse sine function. So that means you're getting something in quadrant 4 rotating clockwise. Remember that, forget about this negative for a moment. With the inverse cosine function, you get something in quadrant 2 if your argument is negative. So looking at the problem, again, it presents a bit of an issue. But once you see that there's a negative here and a negative here, it's really not that bad. So you're going to use this little hint that I gave you where it says, remember that arcsine or the inverse sine function is an odd function. So that means that the inverse sine of, let's say, negative x is equal to the negative of the inverse sine of x. So here, let me make this 5 a little bit better. You can take this negative here that's on the inside and just bring it out like that. So basically, what you can do is you can write this as the negative of the inverse cosine of x is equal to negative inverse sine of this. Now I'm going to make this positive, so 15/17. So now what you can see is that you could multiply both sides by -1 or divide both sides by -1, but basically you can make this positive and this positive, and now the problem is very, very easy. So we're going to go ahead and grab this real quick, and I'm just going to erase this. We'll come back when we're done. We'll come down here and paste this in, and just like before, I'm just going to make a substitution. So this guy right here, I'm just going to let something like theta be equal to the inverse sine of this 15/17. So this is positive now, and so basically this theta is going to be in quadrant 1. So let me put that theta is in quadrant 1. Additionally, we can say that the sine of theta is going to be equal to 15/17. Now remember that this right here is your opposite, and then this right here is your hypotenuse. Well, if I plug in a theta there, essentially I get the inverse cosine of x is equal to theta, and you could take the cosine of each side, or you could use the definition of the inverse cosine function. Basically, you're going to get that x is equal to the cosine of theta. So let's just write here that x is equal to the cosine of theta. And the cosine of theta, again, is going to be the adjacent over the hypotenuse. Well, what's the hypotenuse? We know that's 17. What's the adjacent? A lot of you know that's going to be 8 because this is an 8, 15, 17 special right triangle. So that's what x is going to be. Again, if you want to use a sketch, I have one set up for us. So here's my theta, and I'm going to have an adjacent of 8. I'm going to have an opposite of 15 and a hypotenuse of 17. So basically, let's just go through this real quick. I'll just use x for this, and this is not the x in the problem, but just the x representing the adjacent here. So I'm going to say x squared, and then plus, this would be known, it's 15 squared or 225. That's equal to, this right here is known, that's 17 squared, and that's 289. Let me just write that in now. Basically, if you subtract 225 away from each side of the equation, this is going to cancel. You're going to have x squared is equal to 289 minus 225, that's going to be 64. And then from there, x equals the principal square root of 64, which is 8. So that's where that comes from. And so basically we know that the cosine of this angle theta is going to be the adjacent, which is 8, over the hypotenuse, which is 17. So that's our x in the problem. So coming back, we get x equals 8 over 17. So coming back up here, I want to say x equals 8 over 17. And if you plug that in, you're going to see that it works. So you're plugging in an 8 over 17 here, and basically you're taking the inverse cosine of that, but you have the negative of that. So once you do that, this angle would match this angle. Again, you can punch it into your calculator and check it that way, or you can draw yourself a little sketch if you want to check it that way. All right, so let's take a look at question 23. So we want to solve each equation for exact solutions. We have the inverse cosine of x plus 2 times the inverse sine of the square root of 3 over 2, and this equals pi. So this right here, the inverse sine of square root of 3 over 2, we can replace that with pi over 3. So you can replace that with pi over 3. And again, we can go to the unit circle and think about that there. Your inverse sine function is going to give you something from negative pi over 2 to pi over 2. Just ask the question if you have, let's say, the inverse sine of the square root of 3 over 2. Well, where is the sine value going to be square root of 3 over 2? Well, it's going to be right here, and the associated angle is pi over 3. So I'm going to get pi over 3 out of that guy. Now remember, because I'm not going to come back down here, the cosine of pi over 3 is a half. We're going to need that in a moment. So that's where I got this pi over 3 from. And basically, what you could do, let me just write this as 2 pi over 3, like this. You can subtract 2 pi over 3 away from each side of the equation. Let me slide this down here and say this is 3 pi over 3 like this. This would cancel. I'm just going to erase it. So 3 pi over 3 minus 2 pi over 3 is pi over 3. So this right here is pi over 3. And again, from the definition of the inverse cosine function, if the inverse cosine of x equals pi over 3, then that means that x is equal to the cosine of pi over 3. Again, you can always just take the cosine of each side. You could do it that way as well. But we know that the cosine of pi over 3 is a half. I just showed you that. So this is 1/2. Now, let me erase this. And I'm just going to circle this right here. So x equals 1/2. You can plug this in and check it. So the inverse cosine of a half is pi over 3. So this would be pi over 3. Plus we have 2 times the inverse sine of square root of 3 over 2. We know that's 2 pi over 3 because it's 2 times pi over 3, the result of this. And this is equal to pi, and of course it is. This would be pi plus 2 pi, which is 3 pi, over the common denominator of 3, and 3 pi over 3 is pi. So you get pi equals pi, which is a true statement. So x equals 1/2 is a valid solution. Okay, for question 24, we want to solve each equation for exact solutions. Now you might look at this and think it's a duplicate problem and try to skip it, but it's actually not. So the right side here for question 23 was actually pi. Now it's going to be pi over 3. So this is going to give us a different result. So if we have the inverse cosine of this x here, and plus 2 times, again, we know the inverse sine of square root of 3 over 2. We just saw that was pi over 3. So this would be 2 pi over 3 here. This equals pi over 3. So let me subtract 2 pi over 3 away from each side of the equation. So this would cancel, and you get the inverse cosine of x is equal to pi over 3 minus 2 pi over 3. That is negative pi over 3. So this equals negative pi over 3. Let me stop for a moment. Can I get negative pi over 3 out from the inverse cosine function? No. It gives me something from 0 to pi. If you go back to the unit circle, you're getting something from 0 to pi from the inverse cosine function, and your angle is going to be this guy right here. So this, the angle, is negative pi over 3. So negative pi over 3. That is not in the interval from 0 to pi with both being included, so it's impossible. So coming back up, you can just stop and say there's no solution. Now, if you continued and tried to solve the problem, what's going to happen is when you get your solution, if you try to plug it back in, it won't work. So let's say you continued solving the problem, you didn't realize this, and you took the cosine of each side, and you said that x was equal to the cosine of negative pi over 3. Well, the cosine of negative pi over 3 is the same as the cosine of 5 pi over 3, and we know that's positive 1/2, so you get 1/2 here. But again, if you plug this in, it's not going to work. So basically, if you plug in a 1/2 there, the inverse cosine of 1/2 we know is pi over 3. So this is pi over 3, and then plus 2 times the inverse sine of square root of 3 over 2, we know that's 2, this guy right here, times pi over 3, so 2 pi over 3. Does that equal pi over 3? No, this is a false statement. If you combine these, pi plus 2 pi is 3 pi, so this is 3 pi over 3, which is pi. You get pi equals pi over 3, which is false. So this equation has no solution, and again, that comes from the fact that you got something that was outside of the range of the inverse cosine function, so once you realize that, you need to stop. If you keep trying to solve it, you're going to end up with something that doesn't work if you plug it back in, so there's no solution. All right, let's take a look at question 25 now. So we want to solve each equation for exact solutions. So we know when we encounter this type of problem that it's very tedious if we don't use a little identity. So we have the inverse sine of x plus the inverse cosine of 2x equals 5 pi over 6. You want to isolate one of these. In this particular case, it's going to be a lot easier to isolate the inverse sine of x. So let's say the inverse sine of x is equal to, I'm just going to subtract the inverse cosine of 2x away from each side. So let's say this is 5 pi over 6 minus the inverse cosine of 2x. So what I like to do, and what you'll probably see in a textbook if you're using that, you basically want to take this guy right here and make a little substitution. Just makes it easier to think about things. So you're going to let something like, let's just say theta be equal to the inverse cosine of 2x. And based on that, you can then say that cosine of this angle theta is going to be 2x. So we know the cosine of theta is 2x. We're going to use that in a little while to plug in. Additionally, you can do some analysis here, and you can think about your two restrictions that you're going to have, put them together, and you can narrow down where theta is going to be. Sometimes you can get it into a specific quadrant. Other times you can't, but you can still get some information out of it. So what I'm going to do here is just replace that here, and then I'll look at the restrictions. So the inverse sine of x is equal to 5 pi over 6, and then minus theta. Okay, so we know that from the inverse sine function, you get something from negative pi over 2 to pi over 2, with both being included. So for the first restriction here, I'm going to say that 5 pi over 6 minus theta is greater than or equal to negative pi over 2, and less than or equal to pi over 2. Now, what I'm going to do here, because you have a negative theta, I'm going to multiply everything by negative 1. So basically, this becomes positive. This sign is going to flip. This becomes negative, positive. This sign flips, and this becomes negative. Now, because you want to write this in the order of the number line, essentially, you're going to kind of undo some of the stuff you just did. So you're going to put this as a less than or equal to, and make this a negative, and make this a less than or equal to, and this will be a positive. So now what you would do is add 5 pi over 6 to everything. So I'm going to add it here. So plus 5 pi over 6. I'm going to add it here. So plus 5 pi over 6. And then let me move this down here. So I'm going to add it here. So plus 5 pi over 6. So this right here would cancel. You can just erase it if you want. Makes it a little bit cleaner. And then here you'd multiply this by 3 over 3. So you'd have 3 pi plus 5 pi. So that's 8 pi over 6. And if you think about 8 and 6, there's a common factor of 2. 8 divided by 2 is 4. 6 divided by 2 is 3. So this is 4 pi over 3. Then let me slide this down here. For this one, we're going to multiply by 3 over 3. So this is minus 3 pi over 6. So 5 pi minus 3 pi is 2 pi. So you'd have 2 pi over 6. So 2 pi over 6. And of course, if you divide 2 by 2, you get 1. And if you divide 6 by 2, you get 3. So let me erase this and actually put this like this. So that's going to be one restriction here. So theta is greater than or equal to pi over 3 and less than or equal to 4 pi over 3. So then you're going to say and. You're going to have this second guy here. And that's coming from the range of the inverse cosine function. So theta is coming from the inverse cosine of 2x, whatever that is. So I know that theta is from 0 to pi with both being included because that's the range of the inverse cosine function. So let's go ahead and say that this theta is greater than or equal to 0 and less than or equal to pi. Okay, let me make that a little bit better. So when you think about the intersection of the two, essentially you're looking for, on the left, the larger value. You want the one that's more restrictive, and that's going to work in both. So you're going to say that that's going to be pi over 3 because pi over 3 is greater than 0. Then this is less than or equal to your theta, which is less than or equal to. Here on the right, you're going to want the one that is smaller. So pi is less than 4 pi over 3, so you're going to use that. So if you come to the unit circle and just think about it, this right now is what we know about our angle theta. So it's from pi over 3 to pi, with both being included. We'll figure out more later on, but for right now, that's pretty much good enough. So let's go ahead and grab this and come down here. And I'm just going to move this out of the way. It's probably going to get cut off as we work, but I'll just try to keep it in frame as much as I can. Essentially, at this point, you take the sine of each side, or you could use the definition of the inverse sine function. So you would have that x is equal to the sine of this 5 pi over 6 minus theta. Now I have my difference identity for sine right here, so we're just going to follow that. So x would be equal to the sine of the first guy, so it's the sine of 5 pi over 6. Let me write this out. So the sine of 5 pi over 6, maybe that 5 could be better. Everyone knows that that's 1/2. And then times, you're going to have the cosine of this theta, and then minus the cosine of 5 pi over 6. And hopefully you know that's negative square root of 3 over 2. I'll go to the unit circle in a moment, just in case you don't have one handy. And then times, you're going to have your sine of theta. So again, coming back to the unit circle, if you look at 5 pi over 6, your cosine value is negative square root of 3 over 2, and your sine value is 1/2. And basically, we know that the cosine of theta from earlier is 2x. So we're just going to plug some stuff in and see what we get. So basically, x is equal to, you're going to have 1/2 in the place of sine of 5 pi over 6. So 1/2 times, for the cosine of theta, that's going to be 2x. And then basically you have minus, I'm just going to wrap this because you're going to have a negative involved. So you're going to have negative square root of 3 over 2. I'm plugging that in for the cosine of 5 pi over 6, and then times your sine of theta. So right now you have minus a negative, so I'm just going to change that into plus a positive. Let's put this as a plus here. And essentially, the 2's would cancel here. And so you have x is equal to x plus the square root of 3 over 2 times your sine of theta. Okay, at this point, you can actually subtract x away from each side of the equation. So this cancels and this cancels. I'm going to put a 0 over here. What you're going to get is the square root of 3 over 2 times your sine of theta is equal to 0. So I would multiply both sides by 2 over the square root of 3. Multiply this by 2 over the square root of 3. And of course, this is going to cancel and give me a big fat 1, right? If I multiply reciprocals, I get 1. So you get the sine of theta is equal to 0 times anything is 0. All right, so we just need to figure out what is the sine of theta. All right, so let's come to a little sketch here and think about the sine of theta. So first, let me write what we know. We know that the cosine of theta is equal to 2x. And you could write that as 2x over 1. So basically, we know that this 2x here, that's going to be the adjacent. And we know that 1 here is the hypotenuse. So essentially, you see two different sketches here. I just put them together. And we have one that's going to be for quadrant 1, and we have one that's going to be for quadrant 2. And this is coming from the fact that at this point, we've said that theta is greater than or equal to pi over 3 and less than or equal to pi. So if we end up being in quadrant 1, you're going to use this sketch right here. And basically, you have an adjacent of 2x, you have a hypotenuse of 1, and then you have an opposite of square root of 1 minus 4x squared. If you're in quadrant 2, well, we're going to use this sketch here. Remember, this right here would be your reference angle. So it would be pi minus theta. So let me go ahead and say that this is pi minus theta. And basically, you have an adjacent of 2x, a hypotenuse of 1, and then an opposite of the square root of 1 minus 4x squared. So right now, we really can't tell, based on our information that we have so far, we'll be able to tell later if x is positive or negative, because again, if I'm in quadrant 1, well, this 2x here is going to be positive. If I'm in quadrant 2, well, this 2x here is going to be negative. But we do know that the opposite in each case, which again is the usual y value that we talk about, the opposite is positive whether it's here or here, because we're in quadrant 1 or 2, and that's where sine values are positive, or you could say the y values are positive. So if I want to set up my sine of theta, it's pretty easy. Let me actually use this color here. So for the sine of theta, it's your opposite, which is this guy right here. So the square root of 1 minus 4x squared. And this would be over your hypotenuse, which is 1, so you can leave it off if you want. So this is your sine of theta. So let's go ahead and grab this real quick and come back down here and paste this in. So since the sine of theta equals 0, I can just replace this with 0 and solve this equation. Let me go ahead and grab this real quick and paste this in. Basically, you would just square both sides here. And so you're going to get 1 minus 4x squared, so just the radicand there, is equal to 0. Let's subtract 1 away from each side. So basically this cancels. You get negative 4x squared is equal to negative 1. Let's divide both sides by negative 4. So this is going to cancel. You get x squared is equal to 1/4. And by the square root property, you're going to say that x is equal to, you would have plus or minus 1/2. We can check this, or we can go to the sketch first. So I like going to the sketch and thinking about what I just found. So you have x is equal to plus or minus 1/2. Remember that we said that our theta, so our theta is going to be greater than or equal to pi over 3 and less than or equal to pi. Is it possible for x to be positive 1/2? No, because if this was 1/2, 2 times 1/2 is 1. So that means that this guy right here would be an angle of 0, and that's not in this integral. So x equals 1/2 is not going to work. If you use x equals negative 1/2, if I plug that in there, 2 times negative 1/2 is negative 1. That would put me at pi, so I'd be good to go. I'm in that interval. So that's one way that you could think about it. Again, that's why I like to sketch stuff this way. You could do it a different way if you want. It's kind of up to you. But if you're confused by that, you can always just solve the problem, sketch your triangle in quadrant 1 and don't worry about it, and then just check your solutions. It's not a big deal. So if I come back and say, okay, I'm going to check inverse sine of, let's go with negative 1/2 first. We know that works. Plus the inverse cosine of 2 times negative 1/2. Is this equal to 5 pi over 6? So what is the inverse sine of negative 1/2? Remember, you can always pull this out because the inverse sine function is an odd function. So you could ask the question, what is the negative of the inverse sine of 1/2? And that is negative pi over 6. So basically, this part right here is negative pi over 6. And then plus 2 times negative 1/2 would be negative 1. And the inverse cosine of negative 1 is going to be pi. So let's write that as 6 pi over 6. Does this equal 5 pi over 6? Yes, it does. So this would be 5 pi over 6 equals 5 pi over 6. So x equals negative 1/2. That's the solution you want. The positive 1/2 is not going to work. So let me show you that real quick. If you plug in a positive 1/2 here and a positive 1/2 here, well, the inverse sine of positive 1/2 is pi over 6. And then plus 2 times 1/2 is going to be 1, and the inverse cosine of 1 is going to be 0. So you get pi over 6 plus 0 is equal to 5 pi over 6. And so you can erase this and say pi over 6 equals 5 pi over 6. That is a false statement. So of course, x equals 1/2 is not going to work. And you could have looked at the little sketch there and figured that out if you didn't want to check stuff, or you can check stuff. It really doesn't matter. At the end of the day, we find that the solution is x equals negative 1/2. All right, let's take a look at question 26. So we're asked to solve each equation for exact solutions. And we have the inverse tangent of x plus the inverse tangent of 2x is equal to pi over 4. So for this particular problem, it's going to set up a little bit differently than the other problems we've seen because you have this same inverse trigonometric function here, so the inverse tangent function in each case. So you're actually not going to have to sketch a triangle here. In most cases, when you solve this type of problem, you're trying to figure out, well, what is the sine of theta or the cosine of theta or something like that. Here, you're not going to have to do that. The only thing I would note before we start copying the problem down is that if you think about this x right here and this x right here, you can immediately tell that it's going to be positive. How can you tell that? Well, basically, if you plug in a negative there for the inverse tangent function, you're going to get something in quadrant 4 rotating clockwise, so you're going to get a negative angle measure. So this would be negative. This would also be negative. Negative plus negative is negative. This is a positive, so I know it's not negative. I also know it's not 0 because the inverse tangent of 0 is 0. So you get 0 plus 0, which is 0, and 0 is not equal to pi over 4. So I know here that x is greater than 0. I'm just going to write that right now, that x is greater than 0. And we're going to use this when we come back up after we have solved our problem. So let me write that we have the inverse tangent of x. And I'm going to put this is equal to pi over 4. And then I'm going to subtract this away from each side. So minus the inverse tangent of 2x. So basically, I'm going to use the same strategy. I'm going to let something like theta be equal to the inverse tangent of 2x. And then basically, we can say that the tangent of this angle theta is going to be 2x. So let me actually just copy this real quick, and we'll say the inverse tangent of x is equal to pi over 4 minus, again, this is going to be theta. Theta represents the inverse tangent of 2x, so that's theta. So let me grab this. And again, you don't need any triangles or anything here. You basically just want to go straight into this difference identity for tangent. So if you take the tangent of each side, or again, you can also say that I'm using the definition of the inverse tangent function. Essentially, you get that x is equal to the tangent of this pi over 4 minus theta. So just matching things up with this formula, I know we don't use it that often, but essentially your pi over 4 would be a and your theta would be b. So let's say that x is equal to, and it's going to be hard to keep both of these on the screen. Let me erase this, and then maybe I can slide this up a little bit, and we'll do a little bit better that way. So this would be the tangent of a. So a here is pi over 4, so pi over 4. And then minus the tangent of b. So b here is theta, so the tangent of theta. This is over 1 plus the tangent of a times the tangent of b. Again, a is pi over 4, b is theta. So this is the tangent of pi over 4, and then times the tangent of theta. Okay, so we know a lot at this point. We know the tangent of theta is 2x. So you can erase this and just put in a 2x here, and you can erase this and put in a 2x here. We should also know that the tangent of pi over 4 is 1. So this right here is 1. Most of you know that. Again, you can always pause and go to the unit circle if you need it, but essentially you have the same non-zero number being divided by itself, and so that's how you get 1 for the tangent of pi over 4. So now 1 times 2x is 2x, so this is 2x. I would multiply both sides of the equation. Let me actually tighten this up a little bit. So let me tighten this up a little bit so I can fit everything, and let me move this x over here like this. I'm going to multiply both sides by 1 plus 2x like this. So I'm going to do that here, and then I'm going to do that here like this, and maybe that x could go over here. So let me move this over like that and put the x there. I think that's a little bit better. So basically this would cancel with this, and you get, let's distribute this now. So x times 1 is x, and then plus x times 2x is 2x squared. And this equals 1 minus 2x. So we're going to have a quadratic equation here. So I'm going to move everything to one side. So let's add 2x to both sides, and let's subtract 1 away from each side. So this is gone. We're just going to say this is 0. Let's come down here. And let's say that you're going to have 2x squared plus x plus 2x is 3x, and then minus 1, and this equals 0. Now, you can try to factor this, but you're going to fail. It does not actually factor. So what you actually have to do is use the quadratic formula. So this right here, I'm going to label that as A. This is going to be B. Let's go plus negative here. So that's going to be C. Let me actually write this out so nobody's lost. So A is 2, B is equal to 3, and C is equal to negative 1. It's probably been a while since you used the quadratic formula, so let me write it out. So x is equal to the negative of b plus or minus the square root of b squared minus 4ac, and the whole thing is over 2a. So all you have to do is just plug in. So for the negative of b, b is 3. So you're just going to plug in a 3 here, and let's plug in a 3 here. So a is 2, so that's going to go here, and then that's going to go here. And then c is negative 1, so that's going to go here. Okay, so 3 squared is 9, so let's plug that in there. And then let's treat this as a negative 4, so I'll go plus negative 4 like this. So negative 4 times 2 is negative 8. Negative 8 times negative 1 is positive 8. So this is 9 plus 8, which is going to be 17. So this is 17. Down here, 2 times 2 is 4. So essentially you have two solutions. You have x is equal to negative 3 and then plus the square root of 17 over 4. Then you also have a solution that is -3 and then minus the square root of 17, and this is over 4. Now, you know the square root of 16 is 4, so the square root of 17 is larger than that, so we know that this answer right here, is positive. And I know that this answer right here is negative. So basically, if I think about what's going to work, again, we already said that x is going to be greater than 0. Let me grab this real quick, come back up here and paste this in. Based on our analysis earlier, we know that this solution will not work. So this will not work. You can reject it. Again, you can plug it in and check it if you want. You pretty much need a computer to check this because it can be a little bit complicated. But if you do plug this in with a calculator or a computer, you're going to see that -3 plus square root of 17 over 4. If you plug that in here and then also here, and you look at the left side, you're going to end up with pi over 4. So you get pi over 4 equals pi over 4. So this right here is your valid solution. So we want to look for square root of 17 minus 3 over 4. Let me actually erase this stuff because it's going to be in the way. But this right here is the one that you want. You don't want this one. Again, the negative one, so the negative of the square root of 17 minus 3 over 4, that is not going to work. You can plug that in and see that it gives you a false statement. All right, for question 27, we want to solve each equation for exact solutions. So we have the inverse cosine of x times the inverse sine of x is equal to pi squared over 16. So if you use the little hints here, the hint 1 says use the identity arc cosine of x plus arc sine of x equals pi over 2. So let's write out the inverse cosine of x. And then I'm going to basically subtract the inverse sine of x away from that identity on each side. So I'll say this equals pi over 2 minus the inverse sine of x. And once you do that, this matches this. So you can legally take this right here and plug it in for that right there. So I'm going to have, let me actually reverse the order. I'm going to put the inverse sine of x times the quantity, this guy right here. So pi over 2 minus the inverse sine of x, close that down. This equals, let me make that better there. So this equals pi squared over 16. Okay, let me grab this real quick. I'm just going to read the other hint with you. And basically it says this equation is now quadratic in form and can be solved with a simple substitution and then factoring. So let me come down here and paste this in. It's actually a little bit easier if you substitute first. So you could distribute this first if you want, but I think if you go let something like u or w, whatever you want to use, let's let u be equal to the inverse sine of x. Well, then basically you can erase this and erase this and put this as a u here and a u here. So now you just distribute the u to each guy inside the parentheses. So you're going to get u times pi over 2, or let's write pi over 2 times u like this, and then minus u times u is u squared. So maybe we'll write negative u squared out in front, and then plus pi over 2 times u, and then this equals pi squared over 16. I'm just going to subtract that away from each side, so minus pi squared over 16, and this equals 0. Okay, let me make that a little bit better. So I would multiply everything by -1 here, so this is positive, negative, and positive. Now this is actually something you can solve by factoring. I know it's a little bit complicated when you have a fraction involved, but just try to do it. If you can't, you can always use the quadratic formula. It's not that big of a deal. I know that this is u squared, and again, the coefficient is 1, so I would just put a u here and a u here. Now, if I think about this right here, this pi squared over 16, remember, this comes from this guy times this guy. Okay, so forget about the middle for right now. That's going to work itself out. But if you look at this guy right here and think about multiplying two things together to get to that, well, if I multiplied pi over 4 by pi over 4, I would get pi squared over 16. So now what I would do is just write that in. So this is pi over 4 and then pi over 4. Now, do I want a positive times a positive? No, I actually want a negative times a negative, because if you look at that, I have a negative right there in the middle. Now, if you check this, it actually works. Your first guy, u times u, is u squared. Your outer is going to be minus pi over 4 times u. Your inner is going to be minus pi over 4 times u. If you combine like terms there, you'd have minus 2 pi over 4, which is basically negative pi over 2, and then times u. So negative pi over 2 times u. And then negative pi over 4 times negative pi over 4 is plus pi squared over 16. Okay, let me get rid of this. And basically you can get rid of one of these. You don't need both. You just set this equal to 0, and you're going to solve that equation. So u is equal to pi over 4. That's it. You just add pi over 4 to both sides. Okay, let me erase all of this. And now we can bring this up here. And notice that it says u is equal to the inverse sine of x, right? So we made that substitution. So just substitute back now. So we're going to say that the inverse sine of x is equal to pi over 4. Well, that means that x is equal to the sine of pi over 4. And we know the sine of pi over 4 is the square root of 2 over 2. So x is the square root of 2 over 2. Let's go back up. And this is what we want. So x equals the square root of 2 over 2. If you want to check this, the inverse cosine of square root of 2 over 2 is pi over 4. And the inverse sine of square root of 2 over 2 is also pi over 4. So you get pi over 4 times pi over 4. And that is going to be equal to pi squared over 16. So you can do this like this and say this is pi squared over 16. So either way, that solution of x equals square root of 2 over 2 is correct. Okay, let's take a look at question 28. So we want to find all solutions in radians. And we have here that n is any integer. So that's for the answers here. And basically we have negative 3 plus 2/3 cosine of x is greater than negative 9 plus the square root of 2 over 3. Now let me grab this real quick. I put some hints in here so you can go through this using the test point approach. Go ahead and find the critical values, set up intervals on the number line, and then test inside of each interval to see what works. And then just think about the period to get your general solution. So you can do it that way. But what I'm going to do, because this is a simple problem, I'm just going to get the cosine of x on one side and a number on the other. And we're just going to go to the unit circle and think about the solution. So I think that's a little bit easier in this case. So first off, I want to get rid of this denominator of 3. So I'm just going to multiply both sides of the inequality by 3. So you'd have negative 3 times 3 plus 2/3 times 3 times your cosine of x is greater than negative 9 plus the square root of 2 over 3 times 3. So right here, you'd see that these 3's would cancel and these 3's would cancel. So negative 3 times 3, that's going to be negative 9. And then plus, this would be 2 cosine of x. And this is greater than, over here, you would have negative 9 plus the square root of 2. Now, of course, if you have negative 9 on each side of an inequality, you can get rid of it. For the tutorial, let's just go through and add 9 to both sides of the inequality, just so we can show it. So basically, this cancels and this cancels. And now we have something that's very simple. We have 2 cosine of x is greater than the square root of 2. So let's go ahead and divide both sides of the inequality by 2. And of course, this is going to cancel. And we get the cosine of x is greater than the square root of 2 over 2. So let's go ahead and grab this and go to the unit circle. Okay, so let's come down here and paste this in. So to solve this in this way, just first think about, well, where is the cosine of x equal to the square root of 2 over 2? That's going to be a boundary. So here at pi over 4, you have a cosine value of square root of 2 over 2. And then also here at 7 pi over 4, you have a cosine value of square root of 2 over 2. Now you have to be very careful when you're trying to put your solution together and you want a general solution. When you think about this part right here, so let's include 0, and we're going to go up 2 and exclude pi over 4. So basically, let's just say that x is greater than or equal to 0 and less than pi over 4. So I'll just put this for right now. We'll get the general solution in a moment. Then you have this piece right here. So you have anything greater than 7 pi over 4 going up to and excluding 2 pi. And this is just solving over the interval from 0, and 0 is included, going up to 2 pi. So something like that. Let's go ahead and put or. Here we have x is strictly greater than 7 pi over 4 and less than your 2 pi. Now, if we want to find the general solution, we really have to think about how we can merge this together in such a way that we can go plus 2 pi n, where n is any integer, on each part. So let me actually just erase this, and you're going to have to think about this in a different way. So first off, you cannot say that x is greater than 7 pi over 4 and less than pi over 4. A lot of students try to do that, and that doesn't work. Pi over 4 is not greater than 7 pi over 4. Here's pi over 4, here's 7 pi over 4. If I was rotating like this, this would be pi over 4 plus 2 pi. So basically, you would have pi over 4, and I didn't do that correctly, so let's go pi over 4 plus 2 pi. Let's say that's 8 pi over 4 if I want a common denominator. So that would be 9 pi over 4. So let's put 9 pi over 4, and that's the way you could do it. Another way to do it is actually, let me just erase this for right now. You could also have done this as a negative angle. So if I rotate it clockwise, I can now say that's negative pi over 4. So I could say it's from negative pi over 4 going up to and excluding this pi over 4. So you could say x is greater than negative pi over 4 and then less than this pi over 4. Now we need to think about the general solution. And let's go to the graph real quick. I think this can be helpful. We're working on the cosine of x is greater than the square root of 2 over 2. So if you subtract this away from each side, you get the cosine of x minus the square root of 2 over 2 is greater than 0. So essentially looking at the way I've written this here, you're basically asking, what are the y values that are greater than 0? So where is the graph above the x-axis? Well, we can see the x-intercepts, or where it would be 0. Here's your negative pi over 4, and here's your pi over 4. And again, between those guys, that's where you're going to satisfy that inequality. So this is one of the solutions we came up with. So again, that was x is greater than negative pi over 4 and less than pi over 4. Here's another solution we came up with. So here's 7 pi over 4 and here's 9 pi over 4. And we would go between those two, right? So those guys are not included, but between those two, it would work. So again, how do we find a general solution to where we have this guy and this guy and then this guy and so on and so forth? Well, you could write it like this and go plus 2 pi n on each part, but the way it's actually written in the solution for the problem, we're using this one. So let's go 7 pi over 4 plus 2 pi n. And again, if I added 2 pi to this, I get to 15 pi over 4. If I subtracted 2 pi away from this, I'd be at my negative pi over 4. Let's say this is less than, you'd have your x, which is less than, let's take this one. So your 9 pi over 4 plus 2 pi n. And if I took this 9 pi over 4 and I added 2 pi, I'd get this 17 pi over 4. If I subtracted away 2 pi, I'd have this pi over 4. So this is the solution we're going to go with for the general solution. Let's go ahead and grab this real quick. And let's come up here and paste this in. So this is the one that we want. So we want x is greater than 7 pi over 4 plus 2 pi n and less than 9 pi over 4 plus 2 pi n, where n is any integer. All right, let's take a look at question 29 now. So again, we want to find all solutions in radians, and we're told that n is any integer. That just applies to our answers here. And basically we have 3. We have sine squared x plus 4 sine of x minus cosine squared x minus 2 is greater than 0. So let me grab this real quick. So let's come down here and paste this in. What I'm going to do is basically replace cosine squared x using a little identity. So we know that sine squared x plus cosine squared x is equal to 1. Subtract the sine squared x away from each side. So I'll go minus sine squared x over here, and over here I'll just get rid of it. So basically, this is going to match this. So that means legally, I can plug this right here in for this right here. But you've got to be careful because you have that minus sign there. So this minus these to apply to each guy. So you would have 3 sine squared x plus 4 sine of x, and then minus, let me put some parentheses in here. So you're going to put this whole thing in here. So 1 minus sine squared x, close that down, then minus 2, and this is greater than 0. At this point, we have 3 sine squared x, and then plus 4 sine of x. This minus is going to be distributed to each guy. Let's go plus negative 1 like this, and just show it like that. So you'd have minus 1, and then plus sine squared x. Again, just changing the sign of each guy inside so we can drop the parentheses. And then you have minus 2, and this is greater than 0. So right now you have this 3 sine squared x, and you have sine squared x. So if you add those together, you would have 4 sine squared x. You can always put a 1 there if that's helpful. And then let's go plus 4 sine of x. And then negative 1 minus 2 would be negative 3. So then minus 3, and this is greater than 0. Okay, at this point, you want to find your critical values. So basically, you're going to replace this with equals. So let me put critical values here. So I'm going to say, what if we had 4 sine squared x plus 4 sine of x minus 3 is equal to 0? Well, this guy is quadratic in form. So if something is quadratic in form, you can, generally speaking, solve it with factoring in a trigonometry class. Not always. Sometimes you do have to use the quadratic formula, but always try to factor it first because most of your problems are going to work out that way. So if this is a 4, that leads to a problem because it could be 2 times 2 or it could be 4 times 1. To save a little time, I'm just going to tell you it's going to end up being 2 times 2. So let's go 2 sine of x and then 2 sine of x. Now this is a negative 3, so that's either negative 1 and positive 3, or it's positive 1 and negative 3. So let's think about this. If this right here was a positive 3, so this was a plus 3, and this was a negative 1, would that work? Yes, it would. So if you do your outer, this would be plus 3 times 2 is 6, so 6 sine of x. If you do your inner, this would be minus 2 sine of x. So 6 sine of x minus 2 sine of x, that's your 4 sine of x. And of course, negative 1 times positive 3 is negative 3. So this is the correct factorization. So let's use the zero product property now. So let's go 2 sine of x minus 1 equals 0. Add 1 to each side. This cancels. You get 2 sine of x is equal to 1. Divide both sides by 2, and you're going to get the sine of x equals 1/2. So this right here would be the sine of x is equal to 1/2. Then I'm going to say or. Over here, you have 2 sine of x plus 3 is equal to 0. Subtract 3 away from each side. So this would cancel. You get 2 sine of x is equal to negative 3. Let me erase this. You're going to divide both sides here by 2, and you're going to get that the sine of x is equal to negative 3/2, and that's impossible. So this right here has no solution. So this has no solution because of the range of the sine function. You can't get negative 3/2 out from the sine function because basically the range is from negative 1 to positive 1 with both being included, and negative 3/2 is negative 1.5. So that's just not possible. So let me actually just erase this. You can get rid of the or. So really all I'm going to do is think about where the sine of x is equal to 1/2. So come down to the unit circle. Again, we have sine of x is equal to 1/2. I'm just going to work from 0 to 2 pi for right now. So you have this pi over 6. Again, here's your sine value of 1/2. And then you have your 5 pi over 6. Here's your sine value of 1/2. So you're going to use that to split the number line up into intervals. So we're going to go between 0 and pi over 6. And I'm not going to include anything right now. And then you're going to go between pi over 6. So between pi over 6 and 5 pi over 6. So that's another interval. And then I'm going to go between 5 pi over 6 and 2 pi. So let's go ahead and set that up like that. So I basically need to know, is this guy going to be positive or negative? I'm just going to come back up here. And we know this is a greater than. So I'm going to grab this real quick, come down here and paste this in, and put this right here as a greater than. Now, if you think about this factor right here, it's always going to be positive. Let me put a big fat plus sign there. Now, why is this always positive? Remember, the sine of x, the range for that is from negative 1 to positive 1, with both being included. So let's just say you had 2 times negative 1, that would be negative 2. So that's the smallest I can make this. And then negative 2 plus 3 would be positive 1. So this is always going to be positive. So I don't have to worry about this. So the whole thing will be negative if this is negative, and the whole thing will be positive if this is positive. So basically, I want to know where this is greater than 0. So all I need to do is figure out where this is positive. So you have 2 sine of x minus 1. Where is that greater than 0? Add 1 to both sides. Cancel this and say 2 sine of x is greater than 1. Divide both sides by 2. So it's anywhere where the sine of x is greater than 1/2. So if you come back up, where's the sine of x greater than 1/2? Well, again, right here, it's going to be equal to 1/2 at pi over 6. And right here, it's going to be equal to 1/2 at 5 pi over 6. And then basically in between, your sine value there is going to be greater than 1/2. So if I come here, this would be plus. And then basically here, it's less than 1/2. So this would be a minus or a negative. And then down here, of course, it's less than 1/2. So it would be a minus. So if I think about my intervals, for this first one, it's a negative. The second one is a positive. And the third one's going to be a negative. And that's coming from the fact that this factor right here is going to be negative here. And a negative times a positive is a negative. So the whole thing is negative. Here, this factor would be positive. And a positive times a positive is a positive. So this is a plus. And then here again, it would be negative. A negative times a positive is a negative. So this is negative. Okay, once you have that set up, basically your solution region is going to be between pi over 6 and 5 pi over 6. Neither of those is going to be included because it's a strict inequality. So the way you would do this is you would say that your x is greater than pi over 6, and less than 5 pi over 6. And if you want the general solution, all you have to do, let me slide down here a little bit, is just say that x is greater than pi over 6 plus 2 pi n, where n is any integer. And let's line that up a little bit better. And then basically, it's less than your 5 pi over 6 plus 2 pi n, where n is any integer. Let's grab this, and let's come down here and just paste this in. And I'll just throw that right there so we can know what the solution is. I just cleaned up the inequality we were working with. So at one point after we substituted and cleaned up, we had 4 sine squared x plus 4 sine of x minus 3 is greater than 0. So basically, I'm looking for where the y values are greater than 0. So we know that they're equal to 0. We have this pi over 6, that's an x-intercept. And this 5 pi over 6, that's an x-intercept. So if you look between those guys, you're going to be greater than 0. So here you're greater than 0. And then basically that's going to happen by me taking these guys and adding 2 pi. So pi over 6 plus 2 pi, I'm going to be at that 13 pi over 6. So that's right there. Your 5 pi over 6 plus 2 pi, I'm going to be at 17 pi over 6. And again, you would have a solution between those guys as well. So something like that. So there's a solution as well. And again, this would continue forever and ever and ever. So let's go ahead and grab this solution real quick. So we'll come back here and paste this in. So I'm looking for not this one, but this one. So basically, x is greater than pi over 6 plus 2 pi n and less than 5 pi over 6 plus 2 pi n, where n is any integer. All right, let's take a look at question 30. So we want to find all solutions in radians. And here we're told that n is any integer. So we see the problem, the square root of 3, and then cosine of, we have x over 2, and this is greater than the sine of x. Let's grab this real quick and come down here and paste this in. Now, no matter how you work on this problem, it's going to be tedious. So you could use a half angle formula there, but what I like to do is actually make a little substitution and then use a double angle formula. So the first thing I'm going to do is just subtract the sine of x away from each side of the inequality. So this cancels and gives me 0. So let me write this is the square root of 3, and then cosine of x over 2, and then minus the sine of x, and this is greater than 0. So basically what I'm going to do now is just make a little substitution. So you've seen me do this before. I'm going to let something like u be equal to this x over 2, so x over 2. And then what you can do is multiply both sides by 2 and say 2u is equal to x. So I'm just going to plug in. So for x over 2, I want u. Let's just erase that and put u. And then for x, I'm going to put 2u. So remember at this point, we know that this guy is going to have a period of 2 pi. How do we know that? Well, basically, if you think about the cosine function, this is just the cosine of u. The period is the standard 2 pi. When I think about the sine of 2u, so this guy is sped up. So basically, it's the normal 2 pi period divided by that 2. So that 2 that's multiplying u there. So basically, this is 2 pi over 2. So that's going to be pi. So you want the least common multiple of 2 pi and pi. So that's going to be 2 pi. So basically, what I'm going to do is I'm going to solve the related equation from 0 to 2 pi, where 0 is included and 2 pi is excluded. And I'm going to take those solutions and split my unit circle, or you can use a number line. We're going to end up using a table as well. You're going to split that up into regions, and then you're just going to test something in each region and see if it works. And then we'll go back and substitute again, and we'll have our solution. So it does take a while, but let's just go ahead and get started. So basically, I'm going to replace this with equals. So let's say we have the square root of 3 cosine of u minus the sine of 2u, and this equals 0. Now, you might want to copy this form down as well, because we're going to do a lot of work with this, especially on our table. But what you're going to see is that I'm going to substitute here. So you see that I have sine of 2u, and I have this little identity. So the sine of 2u is equal to 2 sine of u cosine of u. So we're going to take this form right here. So this 2 sine of u cosine of u, and we're going to plug that in right there. So basically, you're going to have the square root of 3 cosine of u minus this guy right here. So 2 sine of u cosine of u. And basically, this would be equal to 0. We want to solve this, again, over the interval from 0 to 2 pi. 0 is included, 2 pi is excluded. So what can we do? Well, basically, you can factor out the cosine of u. So that is going to get pulled out in front of some parentheses. So you're going to have the cosine of u times the quantity. You have the square root of 3 minus 2 sine of u, and this equals 0. Okay, so using the zero product property, you would say that the cosine of u is equal to 0. Then, or, if I think about this factor right here, it's the square root of 3 minus 2 sine of u is equal to 0. I'm going to subtract the square root of 3 away from each side of the equation. That cancels. Let me just actually erase it. So let me slide this over here. So this is the negative of the square root of 3. And at this point, I'm just going to divide both sides of the equation by negative 2. So this cancels, and you get the sine of u is equal to negative over negative is positive, so the square root of 3 over 2. So let me write down here that the sine of u is equal to the square root of 3 over 2. Okay, let me grab this real quick, and let's come down to the unit circle. Again, I'm not looking for the general solution at this point. I'm looking to solve over this interval from 0 to 2 pi, and that's just based on what I'm working with. I saw that the period, again, in terms of u, was going to be 2 pi. So any solutions that I collect from 0 to 2 pi would repeat from 2 pi to 4 pi, and then 4 pi to 6 pi, so on and so forth, and we'll see that when we get to the graph. So basically, if I think about where the cosine of u is 0, so normally you say pi over 2 plus pi n, but again, because we're solving over an interval, you'd say pi over 2 and then 3 pi over 2. And then when you think about where the sine of u is going to be square root of 3 over 2, well, here's your square root of 3 over 2, and that's at pi over 3. And then here's your square root of 3 over 2 again, and that's at 2 pi over 3. So you're going to use this to break the number line up, or actually we're going to use a unit circle here. So you're just going to say between 0 and pi over 3, and I'm not including anything here, so I'm just going between. And then basically you're going to go between pi over 3 and pi over 2, and then you're going to go between pi over 2 and 2 pi over 3, and then you're going to go between 2 pi over 3 and your 3 pi over 2, and then lastly, you're going to go between 3 pi over 2 and 2 pi. All right, so now what I'm going to do is come down to a little table where I've already set everything up for us, just to make it a little bit quicker. So you have something like the square root of 3 cosine of u minus the sine of 2u is greater than 0. So remember in the problem we plugged in for this, we used a little identity. If you want to use the other form, it's fine. You're going to get the same result either way. So basically I'm using this because it's a little bit shorter. Now, when we look at the intervals that are already set up for us, you just pick a value between these two critical values. So somewhere in the interval, do not pick the critical value itself. And you could just plug in with a calculator and see if it's positive. If it is, it's going to work. If it's negative, it's not going to work. And obviously we found where it's 0, and 0 is not going to work in this particular case because it's a strict inequality. So in this interval, we pick pi over 4. So that gives me about 0.22. So that's a positive. Again, we don't care about the value or that it's estimated. We just want to know if it's positive or negative. Here we plug in 5 pi over 12 and we get about negative 0.05. So it's negative. Here we're plugging in 7 pi over 12. We get about 0.05. So this is positive. Then here we plug in 3 pi over 4. We get about negative 0.22. So this is negative. And then here we plug in 7 pi over 4 and we get about 2.22. So this is positive. Now, when I write my solution, it's in terms of u. It is not in terms of x yet. So we made a substitution. So we're going to have to go back and make another substitution. And I probably scrolled down too far. So basically, we're going to start with this right here. Things are going to work. Now, because I'm solving from 0 to 2 pi right now, and 0 is included, 0 will be included in this. Nothing else is going to be included as I'm doing this. So I'm going to say that u, not x, but u right now, is greater than or equal to 0 and less than pi over 3. So as I do these, I'm just going to grab them and come up to the unit circle, paste them in, and I'm just going to highlight things. So from 0 and including 0, going up to and excluding pi over 3. Okay, coming back down, let me actually erase this. The next interval where it works is between pi over 2 and 2 pi over 3. So u is greater than pi over 2 and less than 2 pi over 3. So let me grab this, and I'm just going to paste this in, and I'm going to put or. I'm going to put another one underneath this one, and you'll see why in a moment. But let me go ahead and highlight this for right now. So basically between pi over 2 and 2 pi over 3. So we're just going to highlight that. And then the last area that's going to work, we're going to say that u is greater than 3 pi over 2 and less than 2 pi. So let me grab this real quick and come back down and paste this in. And then I'm going to put my or right here. So let me highlight that. So from 3 pi over 2 going up to and excluding 2 pi. So neither is included there. And basically what you want to do is figure out how you can put this guy together. Okay, so that's the issue. Again, we saw that with the last problem. You don't want to say that u is greater than 3 pi over 2 and less than pi over 3. That does not make sense. It doesn't work. So when you put these two together, you can either make this one negative pi over 2. So in other words, you could say 3 pi over 2 minus 2 pi, so minus 4 pi over 2. So that'd be negative pi over 2. So you can go from negative pi over 2 to pi over 3 with both being excluded. That's fine. You can convert this guy over by adding 2 pi to the angle. So that's what I'm going to do. So basically I'm going to say that this is 3 pi over 2, which is less than u, which is less than, if I do pi over 3, so pi over 3, plus 2 pi, so that's 6 pi over 3. That would be 7 pi over 3. So let's put 7 pi over 3 there. So 7 pi over 3. And essentially that's covering from this guy up to this guy, again, just finding the coterminal angle. Now you might say, well, you're no longer in the interval that you were solving over, the 0 to 2 pi, and that's okay. We're trying to find the general solution, so this is what we're going to have to do. So let me move this up here. We're going to end up adding the 2 pi n to each part here, but let me grab this real quick, and let me just paste this up here out of the way. So coming to a little graph, now you have to keep in mind that I'm just replacing my u with x for graphing purposes, but right now this is really a u. It's not in terms of x where we're getting our final solution yet. I just want you to notice that if you look at the x-intercepts, or where this guy is 0, you're going to see that you have that pi over 3, the pi over 2, the 2 pi over 3. You're also going to have your 3 pi over 2, and those are the solutions we found in our interval from 0 to 2 pi, where 0 is included and 2 pi is excluded. Now notice that when you get to the next cycle, those guys are going to repeat. So pi over 3, if I added 2 pi to that, I get to 7 pi over 3. Then pi over 2, if I added 2 pi to that, I'm at 5 pi over 2. Then my 2 pi over 3, if I added 2 pi to that, I'm going to get to 8 pi over 3. And then my 3 pi over 2, if I added 2 pi to that, I'm going to get to 7 pi over 2. So if you think about the inequality, it was the square root of 3 cosine of x minus the sine of 2x. Where is that greater than 0? So where are the y values greater than 0? Now this is hard to see because of the graph, but again, you can go to Desmos and just make your own. You're going to have this piece right here, which is really, really small. So between pi over 2 and 2 pi over 3, so that's right here. So u is greater than pi over 2 and less than 2 pi over 3. And then you're going to have this piece right here. So between 3 pi over 2 and your 7 pi over 3. So here is your u is greater than 3 pi over 2 and less than 7 pi over 3. And that's why I told you, you could have also done this a different way. So you could have done this right here. So this is negative pi over 2. So negative pi over 2 going up to and excluding this pi over 3. Let me go back. Again, if you make this into a negative pi over 2 by rotating clockwise, so by rotating clockwise and saying that's negative pi over 2, what you're seeing is you can go from negative pi over 2 to pi over 3 with both being excluded, and you could write your solution that way if you wanted to. So coming back, you could have done that if you wanted to. I'm just going to stick with it using this form. Okay, so all we really have to do, let me erase this. All we really have to do is take each part here and add 2 pi n, where n is any integer. So we're going to say that u is greater than, you have the 3 pi over 2 plus 2 pi n, where n is any integer, and less than, you have 7 pi over 3 plus 2 pi n, where n is any integer, then or, you have your u is greater than, we have pi over 2 plus 2 pi n, where n is any integer, we'll say n it's less than 2 pi over 3 plus 2 pi n, where n is an integer. So let me go ahead and grab this. Let me come here to a fresh page. And let me remind you that we let u be equal to x over 2. So if I want x, I need to multiply everything by 2. So just go through here and say that instead of u, I have x over 2. So let me put x over 2 like that. Let me slide this down here like this out of the way. And essentially, if you want x, you have to multiply each part by 2. So multiply this by 2, it goes away. Multiply this by 2, you'd have 3 pi. Multiply this by 2, you'd have 4 pi n. So like that. Let me move this 3 pi down there. And then you multiply this by 2, and you'd have 14 pi over 3. So this is 14 pi over 3. And then multiply this by 2, and you'd have 4 pi n. So that's that there. Let's move this down. Okay, I'm going to do the same thing here. So let's write x over 2, or you could just write x here, and then you're just going to multiply everything by 2. So this just becomes pi, and this becomes 4 pi n, and then this becomes 4 pi over 3. So 4 pi over 3, and this becomes 4 pi n. So just multiplying everything by 2, move this up here, and that's basically your solution. Let's go ahead and grab this. If you want to see this in terms of the original problem, you can see that this is going to work out. So this part right here, you're saying that x is greater than 3 pi. So here's your 3 pi. Let me just go to 3 pi. And basically less than 14 pi over 3, so that's right there. So basically that's, let me do this in a different color. That's this piece of the graph right here. Okay, so you can do it that way. Again, you could have also gotten it from right here. That's really going to be personal preference. So it's this piece right here, but you can add 4 pi n to each part, right? And the reason for that is when you work with this form right here, the period is 4 pi. You have the cosine of x over 2. The period of that is 4 pi. The period of your sine of x is 2 pi. So the least common multiple is 4 pi. So if you take this 3 pi, you subtract away 4 pi, you're at negative pi. So here's negative pi. If you take this 14 pi over 3, you subtract away 4 pi, you're going to be right here at 2 pi over 3. So again, this right here is going to match what happens right there. Okay, so you could have written it that way. So it's the same thing. Let me get rid of this. We're going to stick with it the way that we wrote it. And then the other guy is x is greater than pi. So that's going to be right here. Let me highlight that. And less than 4 pi over 3. So that's going to be right there. Again, that's a really small piece. So it's hard to see. You need to go to Desmos so you can see it. So that's where we're going to be greater than 0 as well. And of course, if you added 4 pi to each part, well, pi plus 4 pi is 5 pi. So that gives you this piece right here. And then if you look at 4 pi over 3 plus 4 pi, that's going to give you this 16 pi over 3. So this is what you want to give for your solution. Let's go ahead and grab this. And let me paste this in here. And I'm just going to slide down and look through and see what we have. So it looks like we want this one right here. So pi plus 4 pi n is less than x, which is less than 4 pi over 3 plus 4 pi n. Or you have your 3 pi plus 4 pi n is less than x, which is less than 14 pi over 3 plus 4 pi n, where n is any integer. So that's the one we want. All right, let's take a look at the quiz. For the first question, we're asked to solve each triangle. We want to round to the nearest 10th. All right, so we can either use this little sketch here or we can use this information here. So we're told that the angle C has a measure of 62 degrees. The angle A has a measure of 97 degrees. And then this lowercase b, which is the length of the side that is opposite of angle B, this is 13 yards. So we need to figure out what is this. This is your lowercase a, the length of this side that is opposite of angle A. And then what is this? This is lowercase c, the length of the side that is opposite of your angle C. We also need to find the measure of angle B. So let's get this one first. So you do 180 degrees minus 62 degrees minus 97 degrees, and you're going to get 21 degrees. Okay, so let's just set this up. We'll go ahead and come down here a little bit, and I'm going to use this guy and this guy. So in other words, I can say that 13 yards, which is again my lowercase b, the length of this side here, over the sine of this angle here, which is going to be 21 degrees. And I could just set this equal to, again, if I want this guy right here, this lowercase a, I would just divide by the sine of this angle here, which is 97 degrees. So the sine of a, which again, this a, the measure of that is 97 degrees. Okay, so just multiply both sides by the sine of 97 degrees, and we can cancel this away over here. I'm just going to put this as equal to here just to save some time. And so we'll punch this into the calculator. And if I'm rounding to the nearest 10th, I get about 36. So let's say this is approximately 36 yards. So let's put this over here. Or actually, we could just leave it like this. I think we can remember it when we go to select the answers. So for lowercase c, let me put this in here. I'm just going to change this to the measure of this angle here. So this is 62 degrees here. Again, this would have been the lowercase c divided by the sine of 62 degrees, multiply both sides by the sine of 62 degrees, and you'd have this set up here. So what we would do is just punch this into the calculator. And if I'm rounding to the nearest 10th, I get about 32. So we'll say that this right here is about 32 yards. All right, let me write this out so nobody's lost. So the measure of angle B, we found that to be 21 degrees. And then the length of this side right here, which again is opposite of this angle C, we'll call that lowercase c. This is approximately 32 yards. And then the length of this side right here, again, opposite of angle A, we'll call that lowercase a. And this is approximately 36 yards. So let me grab this and let's come down to the answers here. I'll just paste that in there. So I'm looking for, in each case, your angle B has a measure of 21 degrees. So let's look at lowercase a and lowercase c. So for lowercase a, I'm looking for 36 yards, so that's here and here. And then for lowercase c, I'm looking for 32 yards. So this is what I want right here. All right, let's take a look at question 2. Again, we want to solve each triangle. We want to round to the nearest 10th. We have the measure of angle A is 59 degrees. the measure of angle C is 91 degrees. And then your lowercase b, which again is the length of this side that is opposite of angle B, that's 21 inches. So we need to figure out lowercase c, that's the length of this side here, which is opposite of angle C, lowercase a, which is the length of the side opposite of angle A, and then we need to figure out the measure of angle B. Let's start out with the measure of angle B. So this is equal to what? 180 degrees minus 91 degrees minus 59 degrees, and that's going to be 30 degrees. So this right here is 30 degrees. Okay, so then we can set this up and say that your lowercase b, again, the length of this guy right here is 21 inches. And we'll put this over, let me make that a little bit better there. The sine of this angle here, which is 30 degrees. Now we know the sine of 30 degrees is a half, but I'm just going to leave this like it is for now. So I'm going to say this is equal to, again, I'm going to shortcut this a little bit. Let's just put lowercase a here. Now we would put lowercase a, the length of this side, over the sine of this 59 degrees here, the measure of that angle A. But to speed this up, you would end up multiplying both sides by the sine of 59 degrees. So let's just do that now. And it would have canceled from over here. So this guy, you just punch this into your calculator, and I get about 36. So this would be approximately 36 inches. So let me put a comma here, and that A is approximately 36 inches. And actually, I'm just going to switch this up and put this as a lowercase c. And now I'm going to use this measure for the angle C. So this is 91 degrees. So key that into the calculator. And I get about 42 if we round to the nearest tenth. So we'll say this is approximately 42 inches. And so let's get rid of this. Let's put a comma there, and I'll actually slide this down just a little bit. I'll put my lowercase c, the length of this side right here, is approximately 42 inches. Okay, let's grab this, come down here. So my angle measure for B is the same in each case, 30 degrees. For lowercase a, we're looking for 36 inches. So looking, it's right there. And then for lowercase c, you've got 42 inches. So this is what we want. All right, let's take a look at question 3. So again, we want to solve each triangle, and we want to round to the nearest tenth. So we're given the measure of angle A is 89 degrees. The measure of angle B is 61 degrees. And then for lowercase a, which is the length of this side here, which is opposite of angle A, that's 8 yards. So for the measure of angle C, again, just do 180 degrees minus 89 degrees minus 61 degrees, and that's going to be 30 degrees. And then to figure out this guy right here, which would be lowercase b, the length of this side opposite of our angle B. And then this would be lowercase c, the length of the side that is opposite of angle C. Again, we're just going to use the law of sine. So we're just going to say that we have this one and this one. So let's go 8 yards. That's going to be my lowercase a, or the length of this side here, over the sine of this 89 degrees. This would be equal to, let's start with this one. So I'm going to put lowercase b. You could go over, again, the sine of this angle measure here for B. So this is 61 degrees, but you're going to end up multiplying both sides by the sine of 61 degrees. So let's scooch this down here and put times the sine of 61 degrees like this. We'll just punch this into the calculator. And if I round to the nearest tenth, I get about 7. So this would be approximately 7 yards. Let me make that y a little bit better there. Okay. So what I'll do is actually erase this and put a lowercase c, and just erase this, and you're going to use this angle measure here for C, which is 30 degrees. Now we know the sine of 30 degrees is a half, so you could replace it with a half if you want, or just punch it into the calculator as is. And if we round to the nearest tenth, it's going to be about 4. So let's say that this is about 4 yards. So let me get rid of this. My angle measure for C is 30 degrees. I'll put that the length of this side here, we'll call that B, or lowercase b to be more specific. This is approximately 7 yards. And then let me slide this down here. My lowercase c, the length of this side here, is going to be approximately 4 yards. So let's grab this real quick. And in each case, the measure of angle C is 30 degrees. So we have that lowercase b should be 7 yards, and lowercase c should be 4 yards. So it's going to be this guy right there. All right, let's take a look at question 4. So now we want to find the area, round to the nearest tenth. And again, with this formula we're going to use, you have to have side, angle, side, where the angle is the included angle, right? So the side, the angle, and the side. So we'll say that the area is equal to 1/2 times, take this side length, so 9 yards, times take this side length, so 10 yards, and then times the sine of that included angle, so it's 119 degrees. So let's key this into the calculator, and I get about 39.4. So let's say this is approximately 39.4, and then you had yards times yards, so that's yards squared, or you can put square yards if you want. So let's just grab this and come down here. So the area is going to be 39.4 yards squared. Again, this is an approximate answer. All right, let's take a look at question 5. So we want to find the area. We're asked to round to the nearest tenth. So here, I know this is a bit small because of the way the triangle is drawn here, but you can see that we're given the angle measure for C is 100 degrees. The angle measure for A is 20 degrees. And then this length right here, this is going to be lowercase c. It's the side length opposite of this angle C. So we are given that that is 7.7 inches. Okay, so we do not have side angle side, right? If we want to find area with that formula, 1/2 times your side length times the sine of the included angle, well, we need side angle side. So you have a side here, an angle here. You could get this side here, or you could do it a different way. You could go side angle side here, whatever you want to do. It's really up to you. So first and foremost, let's get this angle right here. So 180 degrees minus 100 degrees is 80 degrees, and then minus 20 degrees would be 60 degrees. Okay, so that means that we could do the 7.7 inches over the sine of this 100 degrees, like this. And you could set this equal to, again, let's just say that we want this guy right here. So I could go lowercase a over the sine of 20 degrees like this. So you'd multiply both sides by the sine of 20 degrees. So let me get rid of it from over here and slide this down over here. So times the sine of 20 degrees. And if you do this in your calculator, if you round to the nearest tenth, you get about 2.7. So let's say the length of this side right here is about 2.7 inches. All right, so now we can plug into that little area formula. Very simple. So the area is approximately, so you have 1/2 times the length of this guy, so 7.7 inches. Let me wrap that. And then times, we're going to go 2.7 inches, right? The length of this side. And then times the sine of the included angle. So here you have side, angle, side. So the included angle is 60 degrees. So it's the sine of 60 degrees. Now we know that's square root of 3/2, but again, we're just punching this into the calculator anyway. So let's go ahead and say that that's going to be about 9, and then you would have square inches or inches squared. So let's say that this is about 9 inches squared. So let's come down here, and I'm looking for this, so 9 inches squared. All right, let's take a look at the quiz. For the first question, we're asked to solve each triangle ABC. We're also asked to round to the nearest tenth. So we have that the measure of angle A is 85 degrees. And then we have the length for side C, that's going to be 42 yards. Then we have our length for side A, that's going to be 47 yards. All right, so the first thing I would notice here is that, again, this side A is opposite of this angle A. And we've talked about this in the lesson and also the practice test. If this is an acute angle here, well then this side right here that is opposite of this acute angle, if this is greater than or equal to the other side that's given, then you have exactly one triangle. Okay, so let's prove this with the law of sines. I'm just going to start out by finding the measure for angle C. So we can do that by saying the sine of C over the length for that side C. So let's say this is 42 yards. This would be equal to the sine of, we're going to have this angle A. The measure is 85 degrees. This is over the length for this side A. So that's going to be 47 yards. Okay, I'm going to multiply both sides by 42 yards. So let's do that over here. And then I'm just going to cancel this with this. And you can just erase this from over here. You don't really need it anymore. And I'm going to cancel these units here and just punch this into the calculator. And I get about 0.8902. So let me put that this is equal to, again, this is an approximation, 0.8902. If I want to find the measure of angle C, again, I can use my inverse sine function So I can say this is sine inverse of this value right here, so 0.8902. And so that is approximately, let's say rounding to the nearest tenth, about 62.9. So let's say that this is about 62.9 degrees. Okay, now I said that there would only be one triangle here. Let's prove that. So first off, we know that supplementary angles have the same sine value. So I could say that I have 180 degrees minus the measure of this guy right here, which is 62.9 degrees. That would be 117.1 degrees. Okay, so let's say that this is a proposed second, I'll just call it C sub 2 for right now. So a proposed second angle measure for C. Now, if this is possible, then this guy right here, plus the other angle that we're given, the measure for angle A, which is 85 degrees, that should be less than 180 degrees. We're going to see that it's not. If I add 117.1 degrees to 85 degrees, you're going to get 202.1 degrees. Okay, so this is not possible, right? The sum of all the measures of the angles in a triangle is 180 degrees. So you can get rid of that right away. It's not possible. Again, the quicker way to see that is if this guy right here, if you're looking at this side that is opposite of your angle given, if that is greater than or equal to this other side given, and you have an acute angle here, you have exactly one triangle. So this is my C here, and then we can find the measure for my angle B by just doing 180 degrees minus 85 degrees minus 62.9 degrees, and I get 32.1 degrees. Now, the last thing we need to find is our little b, okay, so our little b, and that's going to be what? You can say that this would be, let's use little a, so the length of that side is 47 yards, over, let's use the sine of 85 degrees, so the sine of 85 degrees. And again, this little b here, or the length of that side b, would be divided by the sine of our angle b. So we know the sine of 32.1 degrees. Again, just multiply both sides by that. We're just going to speed this up a little bit. So I'm going to multiply over here by the sine of 32.1 degrees. And I'm just going to punch this into the calculator. And I get about 25.1 yards. Again, if I'm rounding to the nearest tenth. So this is what I get right there. And just looking through my choices. So for the measure of angle C, I want 62.9 degrees. For the measure of angle B, I want 32.1 degrees. And again, for the length of side B, I want 25.1 yards. So I want this guy right there. I did draw a little simple sketch just in case you want to see what the triangle looks like. I always think that this is a good idea just to sketch things. So we know that the measure of angle A is 85 degrees. That was given. And we estimated the angle C to be about 62.9 degrees. And for B, it's about 32.1 degrees. We were given the length of side A to be 47 yards and the length of side C to be 42 yards. And again, the length of side B, we went ahead and estimated that to be about 25.1 yards. Okay, let's take a look at question 2. So again, we're asked to solve each triangle ABC. We want to round to the nearest tenth. So here we're given a measure for angle C of 117 degrees. We're given this side B has a length of 24 centimeters. And then our side C has a length that's 14 centimeters. Okay, so immediately we know that there's not a triangle here. How do we know this? Again, just sketch this out real quick. The angle C here is 117 degrees. So this is an obtuse angle. So this is the largest angle if this was a triangle. The side opposite should be the largest side, right? So this side right here should be greater than this side right here. It can't be equal and it can't be less than. So this guy right here is 14 centimeters. This guy right here is 24 centimeters. So this is not long enough to create a triangle. So we can just go back and just say not a triangle. All right, let's take a look at question 3. So again, we want to solve each triangle ABC. We want to round to the nearest tenth. So here we're given that the measure of angle B is 56 degrees. Our side A has a length that's 32 yards. And our side B has a length that's 29 yards. Okay, so looking at this guy, again, this is an acute angle. This side B here, which is opposite of the acute angle given, that's less than this side A. So here, we really need to use our law of sines, or you could make a sketch and think about the height. It's up to you what you want to do. But I'm just going to use the law of sines and see what we get. So let's go ahead and say that we're going to try to figure out what is the measure of angle A. So the sine of A over the length for little a, so that's 32 yards. This would be equal to, we have the sine of our angle B, that's 56 degrees, over the length of B, so this is 29 yards. Okay, let's just multiply both sides by 32 yards. Let's multiply over here. And I forgot to do my multiplication symbol. So let's cancel this with this, and let's cancel yards with yards. And I'm actually just going to erase this. And we'll just key this into the calculator and see what we get. And I get about 0.914, let's just say 8. We'll stop it there. So let's say that this is about 0.914, let's just say 8. So for the measure of angle A, let's say this is the sine inverse of this guy right here, so 0.9148. So let's punch that into the calculator, and I get about, let's say, 66.2 degrees. So let's say that the measure of angle A is about 66.2 degrees. Now I'm going to call this A sub 1, okay, because we might have a second angle A if we have another triangle. So how do we figure that out? Again, you're going to take 180 degrees and then subtract away this guy right here, so 66.2 degrees. Again, supplementary angles have the same sine value. So this would be equal to 113.8 degrees. So let's say A sub 2 is equal to 113.8 degrees. Let me get rid of this from right here. Do we have a second triangle? Again, take the angle you're given, which is 56 degrees, add it to your proposed second angle. So we'll put 113.8 degrees, and you're going to see, is there room for another angle? So is this less than 180 degrees? Well, if you key this into your calculator, you're going to get 169.8 degrees. So that tells me I do have a second triangle because there's room for another angle. And you could just get it right now. You can say that your C sub 2 is going to be equal to 180 degrees minus 169.8 degrees, and that would be about 10.2 degrees. Let's say that this would be about 10.2 degrees. Okay, so over here, my C sub 1, again, 180 degrees minus 56 degrees minus 66.2 degrees. That gives me a C sub 1 that's about 57.8 degrees. So I keep saying about because all of these guys are approximations. So just keep that in mind. Okay, so all I need to do now is find my little c in each case. So let's call this little c sub 1 and little c sub 2. So the way you do that, I'm just going to use, let me come down here a little bit, my ratio, which is going to be little b, which is 29 yards, over, you're going to have the sine of your angle b, which is 56 degrees. So this is going to be equal to your little c, so we could do c sub 1 or c sub 2. Let's just put little c for right now. And this would be over the sine of whatever the measure of the angle c is. So it's going to be this one for the first triangle and this one for the second. So let's just start off with the first triangle. So I'll just go ahead and say this is c sub 1. And this right here would be the sine of 57.8 degrees. So we know already we'd multiply both sides by the sine of 57.8 degrees. And I'm not even going to show it over here. We know that this would just cancel. So this is my C sub 1 here. And we could just key this into the calculator. And I get about 29.6, and this is yards. So let's say this is about 29.6 yards. And then for this one, I just need to make a slight change. Let's say this is lowercase c sub 2. I'm just going to change this angle over here. And now it's going to be 10.2 degrees. So this is all I really need to do. And I'll just key this into the calculator. Now I'm going to get about 6.2 yards. So let me put this as about 6.2 yards. So let's get rid of this. And I'm just going to grab this information here. And let's paste this in here and then move this up here. So for the first triangle, I'm looking for the measure of angle A to be 66.2 degrees. So it looks like that's going to be here and here. So let me just mark these two for right now. That's what I'm looking for. Then the measure of angle C should be 57.8 degrees. So I have that here and also here. Then the length for my side C should be 29.6 yards. So it looks like it's going to be this one. So let me circle this, and I'm just going to check the other triangle to make sure it matches. So the measure for my angle A there is 113.8 degrees. The measure for my angle C is 10.2 degrees. And then my length for side C is 6.2 yards. So this is the answer we want. Now, just in case you want to see it, I did sketch both triangles. So here is the first one. Again, we were given a measure for angle B of 56 degrees. We were given a length for side B of 29 yards, a length for side A of 32 yards. And then we estimated the measure for angle C to be 57.8 degrees, the measure for angle A to be 66.2 degrees, and then the length for side C to be 29.6 yards. Then for the other guy, again, the only thing that's going to change here is the measure of angle C. We estimated that to be about 10.2 degrees. Then the measure for angle A, we estimated that to be about 113.8 degrees. And then the length for side C, that's about 6.2 yards. All right, let's take a look at question 4. So again, we want to solve each triangle ABC. So we have that the measure of angle C is 41 degrees. We have the length for our side B as 38 miles, and the length for our side C as 32 miles. We would need to figure out what is the measure of angle B. So you'd say the sine of this B over the length for the side B. So this is 38 miles. Then this would be equal to the sine of your angle C. So that's 41 degrees over the length of the side C. So that's 32 miles. Let me go ahead and multiply both sides by 38 miles. So let's do that over here. This would cancel. And then also you can cancel these units away. So the sine of B is going to be equal to this guy right here. Let me just erase these units. Now, again, if you want to speed this up, you could just say that B is equal to the inverse sine of this guy right here. So the sine of 41 degrees over 32 times 38 over here. Again, you can do this in 2 steps if you want, if it's more comfortable for you, but this is going to actually give you a more accurate answer. So let's just do it this way. So I'm going to punch this into my calculator, and I get about 51.2 degrees if I round to the nearest tenth. So let's say that B is about 51.2 degrees. Now, if we have a second triangle, let's just call this B sub 1, and this one would be B sub 2, how do we get this guy right here? Remember, supplementary angles have the same sine value. So you just do 180 degrees minus this guy right here, and that's going to give me a measure for angle, let's call it B sub 2. It's about 128.8 degrees. So now we would need to figure out, is there room for another angle if I had a second triangle, right? So in other words, you take this angle that's given, 41 degrees. So 41 degrees. Add it to this proposed angle here, so 128.8 degrees. If this is greater than 180 degrees or equal to 180 degrees, you don't have a second triangle. If it's less than 180 degrees, well, then you have room for another angle, so you do have a second triangle. So doing this, I would get about 169.8 degrees. So that tells me I do have room for a second triangle. Right now, if you want to get your A sub 2, or the measure of angle A in that second triangle, just take 180 degrees and subtract away 169.8 degrees, and you're going to get about 10.2 degrees. Then for A sub 1, or the measure of A in my first triangle, let's take 180 degrees, subtract away 41 degrees, and then subtract away 51.2 degrees, and you'll get about 87.8 degrees for the measure of angle A sub 1, or the angle A in the first triangle. Okay, so now all I need to do is figure out what is little a. I'll call it little a sub 1, and then little a over here, so little a sub 2. Okay, so in each case, you're going to use that same ratio. So basically the angle that you started with and the side opposite. So let's just say that little c is 32 miles. This is over the sine of that angle C, which is 41 degrees. And let's say that we would have this being equal to, you have your little a, let's just start with a sub 1, over the sine of whatever this angle A is in the first triangle. It's going to be 87.8 degrees. Now you're just going to multiply both sides by this guy right here to clear the denominator. So the sine of 87.8 degrees. So let me just erase it from over here. So if I key this into the calculator, I get about 48.7, and this is in terms of miles. This is when I round to the nearest tenth. So let's say this is about 48.7 miles. Then for my little a sub 2, what I would do is just change this notation here, and then just change this angle. Now I'm working with an angle that's going to be 10.2 degrees. Let's key this in, and I get about 8.6 miles. So let's put about 8.6 miles. And we can actually get rid of this. And I'm just going to copy this real quick. Okay, so looking through my answers, it looks like for the first triangle, the measure of angle B would be 51.2 degrees. So you're going to see that here and then here. The measure for angle A is going to be 87.8 degrees. So here and here. And then for A sub 1, or basically your side A, the length should be 48.7 miles. So that's going to be this guy right here. So let me circle this. And I'm actually going to get rid of this information. I undid my circling, but this is what I want. And just check this to make sure it matches. So my measure of angle A should be 10.2 degrees. Measure of angle B should be 128.8 degrees. And then my side A should be 8.6 miles. So yeah, this is the answer that we want. Just for the sake of completeness, I went ahead and made a little sketch for us. So again, we were given the fact that our angle C was 41 degrees. And we were also given that our side C was 32 miles. And we were given that our side B was 38 miles. Now we estimated that our angle A was 87.8 degrees and our angle B was 51.2 degrees. And then our side A was about 48.7 miles. Now this other guy, which is a little bit harder to see, but basically the only thing that's changing here, you have your measure for angle A is 10.2 degrees. And then your measure for angle B, that's going to be 128.8 degrees. Again, both of those are estimates. And then the length for your side A, this is about 8.6 miles. All right, let's take a look at question 5 now. So again, we want to solve each triangle ABC. We want to round to the nearest tenth. So we're given the measure for angle C, that's 115 degrees. For the length for side B, that's 13 yards. And then for the length for side C, that's 29 yards. We have an obtuse angle here, is 115 degrees. So the side opposite needs to be the longest side. Here it's 29 yards, and the other side given is 13 yards. So we have exactly one triangle. So let's just go into solving this. I think it'll be pretty quick. We'll say that the sine of our angle B over little b, the length for that side, let's say that's 13 yards. This is equal to the sine of our angle C, that's 115 degrees, over little c, so that length for that side C is 29 yards. Let's go ahead and multiply both sides by 13 yards. And this is going to cancel. You can cancel these units here. So I'm just going to say that B is equal to the inverse sine of this guy right here. So the sine of 115 degrees and then times 13, and this would be over 29. Let's just punch this into the calculator, and I'm going to get about 24 degrees. So let's say that the measure of angle B is about 24 degrees. So then the measure for my angle A would be about, you take 180 degrees minus 115 degrees minus 24 degrees, and that's going to give you 41 degrees. Okay, the only other thing I need to figure out is going to be the length for my side A. So let's say this little a here. And again, you would just divide this by the sine of your angle A. So the sine of 41 degrees. Set this equal to, you would have your little c, or the length of the side C, that's 29 yards, over the sine of your angle C, which is 115 degrees. Multiply both sides by the sine of 41 degrees. Let's just cancel it from over here. And let's just key this into the calculator, and I get about 21 yards. So let's say that this is about 21 yards. So looking through, you see that the angles match here, but this one doesn't match. So you actually want this one here. So your measure for angle B is 24 degrees, measure for angle A is 41 degrees, and then the side A has a length that's 21 yards. If you want to look at a little sketch, the measure for angle C is 115 degrees. Then we estimated the measure for angle A to be about 41 degrees and the measure for angle B to be about 24 degrees. Then we said that our side C had a length that was 29 yards. Our side B had a length that was 13 yards, so those were given. And then we estimated our length for side A to be about 21 yards. All right, let's take a look at the quiz. For the first question, we're asked to solve each triangle. We want to round your answers to the nearest tenth. So for the first guy here, we have side angle side. So we have a length for side C that's 23 feet. We have a measure for angle A of 24 degrees. We have a length for side B that's 12 feet. So if you have side angle side, you want to use your law of cosines to first solve for the unknown side. So this guy right here, let's just call it side A. So the length of that guy, let's come down here a little bit. We will say that A squared is equal to, we know this is B squared plus C squared, then minus 2 times B times C times the cosine of the included angle. In this case, that's going to be A. So what I want to do is everywhere I see a B here, I want to plug in this 12 feet. Now forget about the feet. We're just going to plug in a 12. Everywhere I see a C, I'm going to plug in a 23. Again, forget about the feet. And then for A here, this is the angle A, we're going to plug in a 24 degrees. So let's say that A squared is equal to, again, for the B, we're going to plug in a 12. This will be squared plus for the C, we're going to plug in a 23. This will be squared, then minus 2 times 12 for B and 23 for C, and then times the cosine of, again, for the measure of angle A, that's 24 degrees. Let me erase this, and we know that we can just say that A is equal to the principal square root of this guy. We could just key this into the calculator, and I get about 12.9893, and I'll just stop there. If we're rounding to the nearest tenth, it's about 13, and again, this is in terms of feet. So I'll go ahead and say that lowercase a, or the length for side A, is going to be about 13 feet. And let me come back up here. And that's pretty close to there. So let me drag this up here, and I'll just label this right here as 13 feet. Now for the next step, you would typically use the law of sines to figure out the smaller of the two angle measures. So in this case, the angle B is going to be smaller than the angle C. Remember, if angle C ends up being obtuse, and it is going to be, if you use the law of sines, the inverse sine function is not going to give you an obtuse angle. Right? It's going to return something in quadrant 1 for these cases, right? So you're not going to get the right answer. So you want to go with the smaller of the two. Now you could use the law of cosines to solve for this guy right here if you wanted to. Again, that's just personal preference. I'm just going to stick with what the book does, and we'll just use our law of sines. So what I'll do is I'll say that the sine of 24 degrees, so that's the measure of this angle A here, over the length of side A, so we estimated this to be about 13 feet. This would be equal to the sine of my angle B over the length of side B, which is 12 feet. Okay, let me grab this real quick. I think maybe we'll go to a fresh sheet here. So we know already that all you're going to do is multiply both sides by 12 feet. So let's do that over here. And this is going to cancel. And basically your units are going to cancel. And so let's just go ahead and write this in a more quick manner. We'll say that B is equal to the inverse sine of this stuff right here. So you'll have the sine of 24 degrees. Let's say this is over 13 and then times 12 like this. And just key this into your calculator. And I get about 22.05207, and I'll stop there. If you round this to the nearest tenth, you get about 22.1, and this is in terms of degrees. Now this is not going to exactly match the answer given, and I'll explain why in a moment. So let's come back up here. And I'll say that the measure of angle B is about 22.1 degrees. So these problems are generated by a computer. And so in some cases, you're going to have things like this that come up where it's going to be off by, in this case, 0.1 degrees. Okay, but it's not that big of a deal to me. Maybe it's concerning for you, but the computer uses a different method to solve things. It's a more efficient method. And of course, when they do rounding, they have many, many more decimal places than we would use. So that's the difference if you were concerned about your answer. Okay, so going through this guy right here, we can now say that 180 degrees minus 22.1 degrees minus 24 degrees, and I get about 133.9 degrees. And again, the answer given is 134 degrees, so off by 0.1 degrees again. So let's say that the measure of angle B, I'll just go ahead and say it's 22 degrees. Again, it's an estimate either way. I'll say that the length of side A is about 13 feet. And I'll say that the measure of angle C is about 134 degrees. Okay, let's grab this real quick. And we'll come down here. And it looks like I'm looking for this guy right here. And I kind of put this in the way of this. So let me drag this over here. This is the one I want. So the measure of angle C is about 134 degrees, or again, about 133.9 degrees if you followed our steps. And then the measure of angle B is about 22 degrees, or again, about 22.1 degrees if you followed our steps. And the length of side A is about 13 feet. All right, let's take a look at question 2. We want to solve each triangle. Round your answer to the nearest tenth. All right, so we are given side angle side here. So we have the length of side C, that's 10 yards. The measure of angle B is 106 degrees, and the length of side A is 17 yards. So we would want to figure out what is the length of side B. So let's go ahead and say that B squared is equal to A squared plus C squared minus 2 times A times C times the cosine of, again, in this case, the included angle is B. So let's plug in a 17 everywhere there's an A. We're going to plug in a 10 everywhere there's a C. And then we're going to plug in a 106 degrees for this angle B. Again, forget about the yards. We don't really need it. We know it will be in terms of yards when we get our answer. So I'm just going to say that B is equal to the square root of. Again, for A, I'm plugging in 17, so 17 squared. Then plus for C, I'm plugging in 10, so 10 squared, minus 2 times 17 times 10, and then times the cosine of 106 degrees. Let's punch this into the calculator, and I get about 21.9708. So let's just say that's about 22 if we round to the nearest tenth. So let's put here that the length of this side B is about 22, and this will be yards. Now, we know that this is an obtuse angle here. So technically, I could use the law of sines to figure out the measure of this angle or this angle. But to stay consistent with the book, I know that this angle is smaller than this one because it's opposite of the shorter side. Right? So I could just use the law of sines here and just say that the sine of my angle C over the length of side C, which is 10 yards, is equal to, I'll go ahead and say the sine of my angle B, which is 106 degrees, over the length of side B, which is 22 yards. So let me grab that real quick. And And I'll just multiply both sides by 10 yards. So let's do that like that. This will cancel. Yards will cancel. So let's go ahead and say that C is equal to the inverse sine of, basically you would have the sine of 106 degrees times 10 over 22 like this. Let's punch this into the calculator, and I get about 25.9, let's say 086. So again, this is 25.9 if you round to the nearest tenth. So let's come back up, and I'll say that this is about 25.9 degrees. And again, you're going to see that for our answer, it's going to say 26 degrees. Again, it's just how the computer solves things. So let's go ahead and say that the measure of angle A is 180 degrees minus 106 degrees minus 25.9 degrees. So that would be about 48.1 degrees. So let's just write that the measure of angle A is about 48 degrees. Again, if you put 48.1 degrees, you're technically correct as well. And then for the length of side B, let's say this is about 22 yards. And then for the measure of angle C, let's say this is about 26 degrees. Again, you could put 25.9 degrees. That's fine too. Let's grab this. All right, so let's paste this in. So it looks like we want this one right here. So the measure of angle C is about 26 degrees. Or again, you could have put 25.9 degrees. Either one is fine. Then the measure of angle A is about 48 degrees. Or you could have put about 48.1 degrees. And then the length of side B is about 22 yards. All right, let's take a look at question 3 now. So we want to solve each triangle. We want to round your answer to the nearest tenth. So we have our side here. The length of side A is 17 meters. The length of side C is 30 meters. And the length of side B is 18 meters. So what you would do here is use the law of cosines to solve for the largest angle. So what we can do is say that the cosine of C is equal to, you're going to have up here in the numerator, A squared plus B squared, and then minus C squared like this. And this is over 2 times A times B. And this is just coming from me taking the C squared equals A squared plus B squared, then minus 2AB, then times the cosine of C like this, and solving for the cosine of C. So we've done this a bunch already. If you need to pause the video and get to this formula, you can just do that on your own. I think we already know how to do that, so I'm just going to use this formula. So what I'll do here is just plug in for A, B, and C. So A is going to be 17. Again, forget about the meters. B is going to be 18, and C is going to be 30. So let's just say that the cosine of C is equal to, again, for A, I'm going to put 17, so 17 squared, plus for B, it's 18, so 18 squared, and then minus for C, it's going to be 30, so 30 squared, and this is over 2 times, it'll be 17 times 18. Okay, let me get rid of this. I'm actually going to erase this and say that C is equal to the inverse cosine of this guy right here. So let me just drag this up here like this. And this is what we're going to key into our calculator. And I get about 117.966. So let's just say that's about 118 degrees. So let's say this is about 118 degrees. And at this point, you can use the law of sines to find either the measure of angle B or A. It's not going to matter because you've already found your measure for the largest angle. So this guy and this guy, they're not going to be obtuse. So you're good to go. Let's just go ahead and find the measure of angle A. So I'll just say that the sine of A over the length of side A, which is 17 meters, is equal to the sine of our C here. So this is 118 degrees over the length of side C, which is 30 meters. So we know that we would just multiply both sides by 17 meters. So let's do that over here. And this is going to cancel with this. The meters are going to cancel. And maybe I can make that cancellation a little bit better there. And so I'll just say that A is equal to the inverse sine of this guy right here. So the sine of 118 degrees times 17 over 30. Let's key that into the calculator. And I get about 30.022. Let's just stop there. It's about 30 degrees. So I'll say that this is about 30 degrees. Let's get rid of this. And then for the measure of angle B, let's do 180 degrees minus 30 degrees minus 118 degrees. And that gives me about 32 degrees. So let's go ahead and say that the measure of angle A is about 30 degrees. The measure of angle B is about 32 degrees. And the measure of angle C is about 118 degrees. All right, so coming down here, it looks like this is the one we want. Again, the measure of angle A is about 30 degrees. The measure of angle B is about 32 degrees. And the measure of angle C is about 118 degrees. All right, let's take a look at question 4. So we want to solve each triangle. We want to round your answer to the nearest tenth. All right, so we are given side here. So what I would do here is go ahead and say that I'm going to solve for the measure of angle C that's going to be the largest angle because it's opposite the longest side. So again, you can use your cosine of C is equal to, it's going to be a squared plus b squared, and then minus c squared over 2 times a times b. Again, all I did was I took that formula, and I'm running out of room to write stuff. Let me come down here. You take that formula, which is c squared is equal to a squared plus b squared minus 2 times a times b times the cosine of c, and you just solve for the cosine of c. So that's how I got that there. Again, we've done that many times throughout the lesson and the practice test, so I'll let you do that on your own if you need to, but this is the formula that you would get. Let's get rid of this. Let me drag this over here. Maybe we can just fit this in right there. I'll slide down a little bit, and then I'm just going to plug in, and actually, let me just say that c is equal to the inverse cosine. We'll just take care of this right now, like this. And so for a, I'm plugging in 13. Forget about the yards. And let me do that down here as well. And then for b, I'm plugging in 21. Forget about the yards. And let me do that down here. And then for c, I am plugging in a 29. Again, forget about the yards. Okay, so key this into the calculator, and I get about 115 point, let's say 028, and I can just stop there. From rounding to the nearest tenth, it's about 115 degrees. So let's say this is about 115 degrees, and then I can use the law of sines, again, either to get this one or this one. It's not going to matter because I've already found the largest angle here, so this and this, they're not going to be obtuse. Let's go ahead and go with our angle B. So we'll say that the sine of B over 21 yards, that's the length of my side B. This is equal to the sine of 115 degrees over the length of side C, which is going to be 29 yards. Okay, let's multiply both sides by 21 yards. We know it would just cancel from over here. And let me actually just say that the measure of angle B is equal to the inverse sine of this guy right here. Let's key that into the calculator. And actually, let me cancel these units away. And key this into the calculator, and I get about 41.017, and I'll just round that to 41 degrees. So this is about 41 degrees. So if I do 180 degrees minus 115 degrees minus 41 degrees, I get about 24 degrees. So let's say that the measure of angle A is about 24 degrees, the measure of angle B is about 41 degrees, and the measure of angle C is about 115 degrees. So let's grab this real quick. And let's paste this in here. So looking through, it looks like this is what I want. So the measure of angle A is about 24 degrees. The measure of angle C is about 115 degrees. And the measure of angle B is about 41 degrees. All right, let's take a look at question number 5. So now we want to find the area of the triangle using Heron's formula. So we have a length of side A that's going to be 7 meters. The length of side C is 9.3 meters. And the length for side B is 7.3 meters. So Heron's formula says that the area, if you're given 3 sides, is going to be the square root of, you have s times s minus a times s minus b times s minus c. And we saw where this came from in the practice test when we derived it. But essentially, the s is the semi-perimeter, right? So basically, your s is equal to, you add these guys together and you divide by 2. So 7 plus 9.3 plus 7.3, that gives me 23.6. And if I divide by 2, I get 11.8. So basically, all you'd have to do is say that the area is equal to the square root of, you would have your 11.8 times, again, you're going to do 11.8, which is your s minus a. So a is 7, so let's go 11.8 minus 7. Don't worry about the meters. When you work with area, you're going to end up with units squared. So you'll have square meters or meters squared, however you want to say that. So then this is times your s, so 11.8 minus your b, so that's 7.3. And then basically times your s, which is 11.8, minus your c, so that's going to be 9.3. Okay, I'm not going to simplify this at all. I think it's a waste of time. We're just going to key it into the calculator anyway. And I get about 25.242. So if I'm rounding to the nearest tenth, that'd be about 25.2. And again, it's units squared. So let's say 25.2 square meters or meters squared, whatever you want to say. Get rid of this. And I'll say that my area is about 25.2 meters squared. And let's paste this in here. So I'm looking for this answer right here. So about 25.2 square meters, or you could say meters squared. All right, let's take a look at the section quiz. For the first question, we're asked to solve each triangle. We want to round to the nearest tenth. Now here we're given the easy scenario with the law of sines. So we can go straight into it. It's not the ambiguous case. We're given the measure of angle A at 52 degrees, the measure of angle C at 62 degrees, and then this lowercase c, remember this is going to be for the side length that is opposite of this angle C. Okay, so this is given to us as 28 yards. I personally think it's very helpful if you make a sketch. You don't have to, but I think it helps you to visualize what's going on. So I've drawn a little sketch here. Again, if you're making this on your own, it does not have to be perfect. You just need somewhere to put your information down so you can see what's going on. So the first thing I would do here is try to figure out what is the measure of angle B. And we know that the sum of all the measures of the angles in a triangle, it's going to be 180 degrees. So you can just say that it's 180 degrees minus 52 degrees, and then minus 62 degrees. If you key this into your calculator, you're going to get 66 degrees. So let's write that in there, and I'll just erase this and make this a little bit more clean. Now the next thing we want to do is figure out the length of this side and the length of this side. Because this side right here is opposite of my angle B, again, typically we name that with a lowercase b, and we'll name this with a lowercase a, so we need the side length here and the side length here. So what you would do is set up a little ratio with the angle and the side opposite that's known. So in other words, you treat this right here as your ratio, and you say that you want 28 yards over the sine of 62 degrees. So we see that normally as little c, or the length of this side here, over the sine of your angle C, which in this case is 62 degrees. Okay, let me get rid of this. Now, you're going to set this equal to, let me move this down here. We'll say that it's little b, so little b, over your sine of that angle, which is 66 degrees. And you could also set this equal to, you can go little a over the sine of 52 degrees. Let me copy this real quick, and let's just paste this in. You're only going to work on one of these at a time. So let me actually grab this one first. And basically what you would do is multiply both sides by the sine of 66 degrees. So let's say that b is equal to, you would have the sine of 66 degrees times 28 yards over the sine of 62 degrees. So let's key that into the calculator, and I get about 28.9703. If we're rounding to the nearest tenth, that's about 29. And this is in terms of yards. So let's say this is about 29 yards. So let me get rid of this, and I'll just move this up here like this. Okay, now we're done with this part. So now we're going to use this part right here, and we're just going to multiply both sides by the sine of 52 degrees. So we'll say that a is equal to 28 yards over the sine of 62 degrees, and then times the sine of 52 degrees. So let's key that into the calculator, and I get about 24.9893. Let's just stop there. It's about 25 if you're rounding to the nearest tenth, and again, this is in terms of yards. So let's say that this lowercase a is about 25 yards. Okay, let's grab these real quick, and we'll paste these in. So you can use the approximately symbol here, or you can use equals. It really doesn't matter. I'm just going to erase this and put 29 yards. And I'm going to put this as 25 yards. And I'm just going to grab these real quick. Let's put equals here. We know that they're approximations, so we'll just use equals. And we'll grab this real quick and paste this in here. So in every choice, we see the measure of angle B is 66 degrees. So we don't have to look for that. We want to look at the length of side A is listed first. So it should be 25 yards. So it's going to happen here. And then the length of side B should be 29 yards. So this is the answer we want. The measure of angle B is 66 degrees. The length of side A, remember this is the side that's opposite of angle A, this is 25 yards. And then the length of side B, remember this is the side that's opposite of angle B, that's going to be 29 yards. All right, let's move on now and look at question 2. So we're asked to solve each triangle round to the nearest tenth. We have the measure of angle A is 46 degrees. The measure of angle C is 18 degrees. And then our little c, remember this is going to be the side length that is opposite of your angle C, that's going to be 12 yards. Now again, this is the easier case with the law of sines, right? It's not the ambiguous case. We can go straight into it here. And I recommend, again, just making a little sketch. So it doesn't have to be perfect, but just something to write stuff down with. We know we would start by figuring out what is the measure of angle B. So we would say the measure of angle B is 180 degrees. Again, that's going to be the sum of all the measures of the angles in your triangle. So we subtract away 46 degrees and we subtract away 18 degrees. And this gives us 116 degrees. So let me write this in here like this. And let me make this a little bit more clean. I'll actually just write it up here. So the measure of angle B is 116 degrees. Okay, we need to figure out the length of side B and the length of side A. And again, we're going to use this pairing right here to do that. Okay, so I'm going to set up a little ratio. Again, this is going to be little c, or the length of this side right here, which is opposite of angle C, over the sine of my angle C. So just plug in. This is going to be 12 yards right here. And then this down here, this is going to be 18 degrees. So you would set this equal to, you have your little a, or the length of this side right here, right? That is opposite of angle A, over your sine of, again, for angle A, that's 46 degrees. And let's say this is equal to, let me kind of slide this down a little bit over here. We're going to put the little b, or the length of this side right here that's opposite of your angle B. And this is over the sine of, for angle B, that's 116 degrees. Okay, let me grab this real quick and cut this away. I'll actually get rid of that and come down here. We'll just paste this in. And again, we're just going to work on one at a time. So let me start with this one. Now you're always going to use this ratio. So I'm just going to write this in here like this. So if I'm solving for A, I would multiply both sides by the sine of 46 degrees. If I'm solving for B, I would multiply both sides by the sine of 116 degrees. So let's say this is equal to, we'll say A over the sine of 46 degrees. And again, I'm just going to multiply both sides by the sine of 46 degrees. That would go away from over here. Let's just key this into the calculator. And I get about 27.9339. If we're rounding to the nearest tenth, it's about 27.9. And this is in terms of yards. So let's say that A, the length of that side, is going to be about 27.9 yards. Let's just use equals here. So 27.9 yards. Okay, then for B, or lowercase b, the length of that side, it's going to be, again, use this ratio here. So 12 yards over the sine of 18 degrees. Let me erase this so this is more clear here, what we're using. And then basically, you're going to multiply by the sine of 116 degrees. Okay, multiplying both sides by that would clear the denominator over here. So that's why we just have the b. Okay, so if we key this into the calculator, I get about 34.9027. If I'm rounding to the nearest tenth, it's about 34.9. And this is in terms of yards. So let me get rid of this, move this down. I'll say it's about 34.9 yards. Let's grab this real quick, come back up. And I'm just going to paste this in maybe down here and move this down here so we have everything together. I'll just erase this and put this in as 34.9 yards. I'll erase this and just put this as 27.9 yards. Okay, let's grab this real quick. We will come back up here and look for our answer. So everywhere it says the measure of angle B is 116 degrees, so don't even worry about that. For the length of side A, it should be 27.9 yards. So that's right there. And then for the length of side B, it should be 34.9 yards. So this is the answer we're looking for. The measure of angle B is 116 degrees. The length of the side A, remember this is the side opposite of angle A, this is 27.9 yards. And the length of side B, this is the side opposite of angle B, this is going to be 34.9 yards. All right, let's take a look at question 3. So we're asked to find the area. We want to round to the nearest tenth. So in this case, we have the length of side B, that's 14 feet. The length of side A, that's 10 feet. And then we have the measure of angle C, that's 78 degrees. So if you make a little sketch, you can see that you have side, angle, side. And if you have side, angle, side, you can use that little formula. So the area is equal to, so in this particular case, you're going to have 1/2 times the length of side A, let's just put lowercase a, times the length of side B, let's put lowercase b, and then times the sine of the included angle, so that's going to be C. So let's just plug in. So the length of side A is 10 feet. So this is 10 feet. Forget about the feet. We know it's going to end up being feet squared or square feet. You can just leave it off. Then for B, the length of the side right here, that's going to be 14 feet. So again, I'll just put 14 in there. And then the sine of, for the measure of angle C, that's 78 degrees. So let's key this into the calculator, and I get about 68.4703. Let's just stop there. We're rounding to the nearest tenth, so about 68.5. So let's put 68. Let me just erase this and put 68.5. And again, if you're working with area, it's always units squared. So here we have feet. So we want to go feet squared like this, or you could write square feet, whatever you want to do. Doesn't matter. So let's go ahead and grab this and come back up here, and we'll paste this in. So the area I'm looking for is 68.5 square feet, or feet squared. Again, however you want to say that. All right, let's take a look at question 4. So again, we're asked to find the area. We want to round to the nearest tenth. So we have the length of side B, that's 10 inches. We have the measure of angle C, that's 31 degrees. And the measure of angle B is 129 degrees. Okay, let's look at a little sketch. So right now we don't have side angle side, but very easily I could find out the length of this side right here. Let's just call it lowercase a. And then we could use our side angle side formula for area. So what I would do is use this guy right here, this angle, and this side opposite to set up a little ratio. So I'll go ahead and say that little b, or the length of this side right here, over the sine of my angle b is equal to, you're going to have this little a, or the length of this side right here, over the sine of this angle a right here. So what do I know at this point? I know that the length of this side right here, again, that's little b. We're going to say that's 10 inches. And then the angle B is 129 degrees. So let's put that in there. And then for little a, I don't know what that is. I'm trying to solve for that. For the measure of angle A, I can go 180 degrees minus 129 degrees minus 31 degrees. And that's going to be 20 degrees. So let's put this in here as 20 degrees. And you can multiply both sides by the sine of 20 degrees. Let me get rid of that from over here. And I'm actually just going to slide this down a little bit and say times the sine of 20 degrees. Let's key that into the calculator. And if I round to the nearest tenth, I get about 4.4. And this is in terms of inches. So let's say 4.4 inches. Now, get rid of this. At this point, you have side, angle, side. So you can use your formula. So we'll say the area is equal to, again, it's 1/2 times, in this case, this is lowercase b that you're working with, this side right here. And this side right here is lowercase a. So it's the same formula we used last time. It was lowercase a times lowercase b times the sine of your angle C. So we're just going to use that same thing. So let's just plug in a 4.4 here. And let's plug in a 10 here. And then let's plug in a 31 degrees here. And let's just key this into the calculator. And I get about 11.3308. And if I round to the nearest tenth, it's about 11.3. So let's erase this. And I'll just say that this is about 11.3. And again, this is going to be in terms of inches squared, or you could say square inches. So let's just write it like this. We'll grab this, come back up, paste this in. And so the area is going to be about 11.3 inches squared, or again, square inches. Okay, let's take a look at question 5. So here we're asked to state the number of possible triangles that can be formed using the given measurements. So we're told that the measure of angle B is 19 degrees, the length of side A is 29 inches, and the length of side B is 14 inches. Now, this is the ambiguous case. We have side-side angle. And so what you could do is immediately go into solving this guy, and then you'll figure out, do I have no triangle, one triangle, or two triangles? So that's one way you can do this. The other thing you can do, we talked about this in the lesson, you could make a simple sketch, and this sketch is not meant to be accurate. It's just something where you're putting down some information. You're thinking about, do I have no triangle, one triangle, or two triangles? This is a little bit quicker if you're just asked that question. So we know that if this guy is your angle given, and this is the side opposite, let me label this. So this is B is equal to, and this is A is equal to. So here, this side that's opposite of this angle given, if this is less than the height, you will not have a triangle. So in other words, if B is less than H, then this is no triangle, or I just put none there to be shorter, okay? If this length right here is greater than the height, and it's less than this other side here, well, then you have two triangles. So in other words, if B is greater than H and it's less than A, that's two triangles, okay? Now, the other scenario would be that this guy right here is greater than or equal to this guy right here. So let's say that B is greater than or equal to A. well, this would be one triangle. And the other scenario would be that B is exactly equal to the height. In that case, you have a right triangle. Okay, but we're not going to see that in this scenario. So do we have one triangle, two triangles, or no triangle? Well, let's think about the height real quick. Let me get rid of this. So to find the height, I'm just going to say that the sine of 19 degrees is equal to, again, we're thinking about this right triangle right here. Okay, so this is a right triangle here. So the opposite is h over the hypotenuse. That's going to be 29 inches. Multiply both sides by 29 inches. And I'll get rid of it from over here. Just punch this into your calculator, and you're going to get about 9.4 inches if you round to the nearest tenth. So let me say this is about 9.4 inches here. And so that tells me I'm going to have exactly two triangles, right? Because again, in this particular case, you have that this side length B is going to be 14 inches, and it's greater than the height, which is 9.4 inches, and it's less than this other side length here, which is 29 inches, right? So in other words, this would end up looking something like this for one triangle, and then you could swing it back over here and say that another triangle would be formed. I don't know where it's going to be. This is just a simple sketch, but essentially you're going to end up with two triangles, okay? So let's come up here and we can actually prove that real quick. We'll start by just trying to find the measure of angle A. So we'll say the sine of A over the length of side A, that's 29 inches. This would be equal to the sine of your angle B over the length of side B, which is 14 inches. And for this one, we know this value, so this is 19 degrees. Let me multiply both sides by 29 inches. Let me get rid of this from over here. And I'm just going to cancel these units away and just say that A is equal to the inverse sine of this guy right here. Let me just copy this and bring this in here. Maybe we can just get rid of the units to make it a little bit cleaner. Close this down and get rid of this. Let's key this into the calculator. I get about 42.4 degrees. So let's say A sub 1 is about 42.4 degrees. And again, what do? We know that B is hard-coded to be 19 degrees. So what you would have is a C sub 1 here. And let's just figure that out. So that's 180 degrees minus 42.4 degrees minus 19 degrees. And that would be 118.6 degrees. So this is one triangle. I'm not going to solve the whole thing. You could figure out what lowercase c is if you want, but that's up to you. Let's come over here and think about the other triangle. We know that supplementary angles have the same sine value. So in other words, I can go for A sub 2, 180 degrees minus 42.4 degrees. So that gives me 137.6 degrees. So put in your B there. This is 19 degrees. And what you want to do to check for two triangles, add these guys together. If it's less than 180 degrees, then you have another triangle. If it's 180 degrees or more, then you don't have a second triangle. So when I add these guys together, I get 156.6 degrees. So we know we would have a second triangle. So coming in here, C sub 2, this would now be 180 degrees minus 156.6 degrees. This would be 23.4 degrees. And again, if you want to continue and find this lowercase c sub 2 in this case, you can do that. But this would be the angle measures for your first triangle, and this would be the angle measures for your second triangle. So we can conclude that there's going to be two triangles. All right, let's take a look at question 6. So here we want to state the number of possible triangles that can be formed using the given measurements. We have the measure of angle A is 42 degrees, the length of side A is 37 meters, and the length of side C is 26 meters. So immediately you see that the length of side A is greater than the length of side C. You can just say that there's one triangle. Again, if you wanted to prove this, you can just go into the sine of 42 degrees, so the sine of A over the length of side A, that's 37 meters. This would be equal to the sine of your C over the length of side C, which is 26 meters. Multiply both sides by 26 meters. Let me get rid of it from over there. You can just cancel these units away. And let's get rid of this actually. I'm going to slide this down and say that C is equal to the inverse sine of this. Let's key that into the calculator, and I get about 28 degrees. So let's say that the measure of angle C is about 28 degrees. Now, if there's room for another triangle, again, supplementary angles have the same sine value. So go ahead and say that 180 degrees minus 28 degrees would be 152 degrees. So let me put C sub 2 would be 152 degrees. Now, here's the problem. If you take the measure of angle A, let me put A here, it's 42 degrees. If you add these two together, it's going to be greater than 180 degrees, which is not possible in a triangle. 152 degrees plus 42 degrees, that's 194 degrees. So you can mark this out right away. A second triangle is not possible. So basically here, your measure for angle C would only be 28 degrees. And you can go through and solve the triangle if you want, but it just asked us for the number of possible triangles. And here we're just going to have one triangle. All right, let's take a look at question 7. So again, we want to state the number of possible triangles that can be formed using the given measurements. So we're given that the measure of angle A is 103 degrees, the length of side C is 36 inches, and the length of side A is 29 inches. So immediately you know the answer here is none. How do you know that? Again, when you think about an obtuse angle, it has to be the largest angle in a triangle. We know that the largest angle is going to be opposite the longest side. This right here is the opposite side, and it's not the longest side. This is 29 inches. This is 36 inches. So this is not going to be possible for us to make a triangle here. So we just select none. Okay, let's take a look at question 8. So now we want to solve each triangle and round to the nearest tenth. We're given the measure of angle A is 83 degrees. The length of side C is 25 inches, and the length of side A is 29 inches. So remember, these guys form a pair. And you can see that this 29 inches is greater than this 25 inches. So immediately I know that it's only one triangle that's going to be possible here, okay? Now you can go through and we're going to prove this, but let me just start solving this. So we have that the sine of my angle A, which is 83 degrees, over the length of side A, which is going to be 29 inches. This would be equal to the sine of my angle C over the length of side C, which is going to be 25 inches. So multiply both sides by 25 inches. Let's do that over here. Let's get rid of this over here. Let's cancel these units away. And actually, I'm just going to get rid of this and say that C is equal to the inverse sine of all of this. Let me just copy this and move this over here. We'll just key this into the calculator. And I get about 58.8 degrees. So let's say that the measure of angle C is about 58.8 degrees. Now again, if you didn't understand this concept earlier of why we said there's one triangle, you can go through and try to set up the second one, right? So you can say, okay, well, the other guy for C is 180 degrees minus 58.8 degrees. So that would give me 121.2 degrees. And what happens is you have an 83 degree angle there plus 121.2 degrees there. Well, that's greater than 180 degrees, right? So the second triangle is not possible, so you can just get rid of it, okay? So now what I would do is I would say that the measure of angle B is going to be 180 degrees minus 83 degrees minus 58.8 degrees, and that's going to be 38.2 degrees. So we have that. And then I need the length of side B, so that equals what? And you can take, again, this ratio here. You have the length of side A, which is 29 inches, over the sine of your angle A, which is 83 degrees. This would be equal to the length of side B over the sine of my angle B, which is about 38.2 degrees. Let's multiply both sides by the sine of 38.2 degrees. Get rid of it from over there. Let's punch that into the calculator. And I get about 18.1 inches if I round to the nearest tenth. So let's say this is about 18.1 inches. So I'm just going to show you a quick sketch so you can see what it looks like. So again, the measure of angle C is 58.8 degrees approximately. The measure of angle A that was given to us as 83 degrees. The measure of angle B is about 38.2 degrees. And then the length of side A, we know that's 29 inches. The length of side C, we know that's 25 inches. And the length of side B is about 18.1 inches. So coming back here, it looks like I want to select this guy right here. The measure of angle C is 58.8 degrees. The measure of angle B is 38.2 degrees. And the length of side B is about 18.1 inches. All right, let's take a look at question 9. So here we want to solve each triangle ABC. We want to round to the nearest tenth. So we see here that the measure of angle A is given as 50 degrees. The length of side C is 30 yards. And the length of side A is 20 yards. What we want to do is first think about, okay, this guy and this guy, these are a pair. You notice that this 20 yards here is less than this 30 yards here. Now you could stop and make a sketch and figure that out first, or you could try to go into solving it. It's really up to you. What I'm going to do is just show you both ways. So what we would do is say that the sine of this 50 degree angle here is the opposite, which is your height, over the hypotenuse, which is going to be 30 yards. So let's just go ahead and multiply both sides by 30 yards. So your height would be equal to 30 yards times the sine of 50 degrees. Let me erase this from here. Let's key this into the calculator. And I get about 23 if I round to the nearest tenth. So let me put 23 yards. Now, the problem is that the length of this side right here, which is 20 yards, is going to be less than the height, so we cannot make a triangle here. So no triangle will exist. So you can come up here and just select not a triangle. The other way you could have done this, you could say that, okay, well, I have the sine of my angle A, which is 50 degrees, over the length of side A, which is 20 yards. You could say this is equal to the sine of my angle C over the length of side C, which is 30 yards. So let's multiply both sides by 30 yards. Let's get rid of this over here. And we're going to cancel these units away. And just key this into the calculator, and you're going to see something funny. I get about 1.1490, and you could just stop there. We know that the sine value is not going to be greater than 1, right? If the sine of C was, let's say, 1, well, we know that C is a 90-degree angle, but it can't be greater than 1. Here we have about 1 point, let's just say 1. So that's not possible, so we know that this is not a triangle, okay? So that's just two different ways that you can go about it. You can make yourself a little sketch, or you can just try to solve the triangle, and you get nonsense, so you can just stop and say, not a triangle. All right, let's take a look at question 10. So here we want to solve each triangle ABC. We want to round to the nearest tenth. So we have that the length of side B is 26 kilometers. The measure of angle A is 123 degrees. And the length of side C is 17 kilometers. Okay, so once again, just make yourself a little sketch. You can see you have side angle side. And so you want to use the law of cosines here. Let's first find the length of this side right here. We'll call it lowercase a. So you can say that a squared is equal to, you're going to have b squared plus c squared, then minus 2 times b times c times the cosine of that angle A. So let me put that like that, and we'll just fill in what we have. So actually, I'll just take the square root now. I'll say a is equal to the principal square root of this stuff. So the length of side B is going to be 26 kilometers. Let's just leave the kilometers out. We know it's going to end up being kilometers, so we'll just leave the units out. We'll just say it's 26, and this is squared, plus the length of side C is 17. Again, forget about the kilometers. So 17 squared minus 2 times, you have 26 times 17 times the cosine of, for the angle A, it's 123 degrees. So let's just key this into the calculator. So I get about 38.0323. Let's just stop there. We're rounding to the nearest tenth. So let's say it's about 38. And this is in terms of kilometers. So let me get rid of this and get rid of that and say that this is about 38 kilometers. And I'll just write this up here. Lowercase a, for the length of this side right here, that's going to be about 38 kilometers. Now, the next thing you'd want to do is find the measure of angle B and the measure of angle C. Now, typically, you want to find the measure of the smaller angle if you're using the law of sines, because remember, if you use the inverse sine function, you can't get an obtuse angle out of that, okay? But you already have your obtuse angle here, so that means this is going to be acute and this is going to be acute. So you don't have that issue, but just to stay consistent, I know that this angle right here is opposite the shorter side, so what I would do is just find the measure of angle C first. So we'll say that the sine of C over the length of side C, which is 17 kilometers, is equal to, we'll go ahead and say the sine of 123 degrees over the length of this side right here, which would be 38 kilometers. And I'll multiply both sides by 17 kilometers. Let me get rid of this from over here. And basically, you can slide this down and say that C is equal to the inverse sine of this guy right here. Let me just slide this down, and let me show these units as canceling. And I get about 22 degrees if I round to the nearest tenth. So let's say this is about 22 degrees, and I'll put this in here, about 22 degrees. Okay, for the measure of angle B, we're just going to say that it's 180 degrees minus 22 degrees minus 123 degrees, and so that would give me about 35 degrees. So let's put that in there, and let's grab this real quick. Let's paste this in here. So let's look at our choices. So this one has the measure of angle B as 35 degrees, and so does this one. And this one has the measure of angle C as 22 degrees, and so does this one. This one has the length of side A as being 38 kilometers, so this is what we want. All right, let's take a look at question 11. So here we want to solve each triangle, and we want to round to the nearest tenth. All right, so the length of side A is 18 yards, the length of side B is 30 yards, and the length of side C is 17 yards. So if you make yourself a little sketch, again, the first thing you'd want to do is figure out the measure of the largest angle using your law of cosines, okay? So that's going to be the measure of angle B because it's opposite of the longest side here, okay? So what I would do, let me come down here. We would say that B squared is equal to A squared plus C squared minus 2 times A times C times the cosine of the angle B. Now what you want to do is solve this for this part right here, right? The cosine of B. That way we can figure out what that is. You can use your inverse cosine function and find out the measure of angle B. So let's just go ahead and say that this is going to be B squared minus A squared minus C squared. And then this would be equal to negative 2AC times the cosine of B. So let me get rid of this. And I'm going to divide both sides by negative 2AC. So let me get rid of this. So this is going to be my cosine of B. So this guy right here. Now to plug in for the length of side B, it's 30 yards. Forget about the units. I'm just going to plug in a 30 here. So this is my 30 there. For A, I'm going to plug in 18. So I'm going to plug that in there and then also there. For C, I'm going to plug in 17. So there and then also there. So let's key that into the calculator. And actually what you can do, let me slide this over just a little bit and get rid of this equal sign from here. I can say that the measure of angle B is going to be equal to the inverse cosine of this guy right here. Let's key this into the calculator. So I get about 117.9664. Let's round that to the nearest tenth. It's going to be about 118 degrees. So let me get rid of this and say this is about 118 degrees. Then you can use your law of sines to figure out this one or this one. Again, I've already figured out the largest angle measure, so I don't have to worry about using the law of sines here. I'm going to be good to go. So I'll just work on the measure of angle C. So I'll say that the sine of C over the length of side C, which is 17 yards, is equal to, we're going to have the sine of 118 degrees over the length of side B, which is 30 yards. So let's multiply both sides by 17 yards. I'll just get rid of it from over here. And actually, I'll say that C is equal to the inverse sine of all of this. Let me cancel those units away. Let's key that into the calculator. And if I round to the nearest tenth, I get about 30 degrees. So let's say that this is about 30 degrees. And let me write these out so we have them. So the measure of angle B is about 118 degrees. The measure of angle C is about 30 degrees. And then the measure of angle A is going to be 180 degrees minus 118 degrees minus 30 degrees. So it's about 32 degrees. So this is about 32 degrees. Let's paste this in here. So I'm actually looking for this first one right here, where we say the measure of angle B is about 118 degrees, measure of angle C is about 30 degrees, and the measure of angle A is about 32 degrees. All right, for question 12, we want to use Heron's formula to find the area of our triangle. We're given these three side lengths here. So the length of side A is 15.8 miles, the length of side B is 13 miles, and the length of side C is 15 miles. You can make a sketch, although it's not really necessary here. This is something I just did with a computer, so it's pretty quick. But in this particular case, if you want to find the area with Heron's formula and you're given side, 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 you don't really need a sketch. So let's just say that this is equal to the square root of, remember, S is the semiperimeter. We'll figure that out in a moment. So times the quantity S minus A, times the quantity S minus B, times the quantity S minus C. Now we know that S, the semiperimeter, is 1/2 times this quantity. You're going to take 13 miles. Just leave the units off. So 13 plus 15.8 plus 15. So you're adding all the side lengths up in there. If we key this into the calculator, this sum right here is 43.8. And if I multiply it by 1/2, or you could divide by 2, it's 21.9. So let's say that this is 21.9. Now, let me actually erase this and redo it because you need a lot of room to write these things in. So this is the square root of, again, your S is 21.9 times the quantity, 21.9 minus the length of side A is going to be 15.8. Forget about the miles. We're just going to leave it off. We know that area is always units squared. So we know that this would be square miles or miles squared, however you want to say that. So then this is going to be times, you're going to have 21.9 minus, for the length of side B, that's going to be 13. And let me slide this down so we have enough room. And then times 21.9 minus, for the length of side C, that's going to be 15. Okay, forget about the mouse. Okay, so let's just key this into the calculator, and I get about 90.5746. So let's just say that's about 90.6 if we round to the nearest tenth. So we will say that the area is about 90.6, and this is miles squared, or you could say square miles, whatever you want to do. So we'll come back up here, and it looks like in this case we wrote out square miles. So you could change it to that or leave it like this, it doesn't matter. So we want this one where it says 90.6 square miles or miles squared. Again, however you want to say that. All right, let's take a look at the quiz. For the first question, we're asked to find the magnitude and direction angle theta for each vector. Here we have our vector A, and basically it's given in component form. So the horizontal component is 12 and the vertical component is negative 16. Let me make that angle bracket a little bit better there. Let me grab this real quick and go to a little sketch. So I'm just going to paste this in right there. So if you want to find the magnitude, again, the formula is very simple. Let me make this arrow a little bit cleaner here. It's just the principal square root of, you take your horizontal component, which is 12, and you square that, that's 144. And then plus you take your vertical component, which is negative 16, and you square that. That's going to be 256. So 144 plus 256, that's going to be 400. And of course, if you take the principal square root of 400, you're going to get 20. So that's going to be the magnitude of my vector A. Now, for the direction angle, remember, this guy is going to be in quadrant 4. So this is going to be a little bit tricky. Okay, so that's my direction angle theta. Now think about one complete rotation is 360 degrees. All you really have to do is take that 360 degrees and then subtract out this angle here. Let's just call it beta to keep it simple. And let me form a little right triangle here. And let's say that the tangent of beta is equal to, forget about the fact that this is negative. I'm just going to work with positive values. So I'm going to say that this opposite here is going to be 16, not negative 16, over the adjacent, that's going to be 12. Of course, you could divide each guy here by 4. 16 divided by 4 is 4, and 12 divided by 4 is 3. So you would say that beta is equal to the inverse tangent of 4 over 3. So key that into the calculator, and you get about 53.13 degrees. So let's get rid of all of this, and I'm just going to say that this angle is about 53.13 degrees. Maybe I can make that a little bit cleaner there. Okay, so all the way, one complete rotation, that's 360 degrees. So theta is approximately 360 degrees minus this part right here that we need to take out. So that's 53.13 degrees. So if I key that into the calculator, I get about 306.87 degrees. So let's say this is about 306.87 degrees. So that's the measure of that direction angle there. So let's grab this and we'll come back up here and paste that in. So I'm looking for a magnitude of my vector A of 20 and a direction angle theta of about 306.87 degrees. So we want that guy right there. All right, let's take a look at question 2. So again, we want to find the magnitude and direction angle theta for each vector. So for the vector v, again in component form, the horizontal component is 12. The vertical component is negative 35. So let's paste this in here. For the magnitude of your vector v, again, it's the principal square root of, you're going to go the horizontal component, which is 12 squared, plus the vertical component, which is negative 35 squared. Just key this into the calculator, and you're going to get 37 as the result. So that's your magnitude for the vector v. And then this guy, again, is going to be in quadrant 4. So we already know how to deal with this. So let's say that this is my direction angle theta. Let's put this as theta. And essentially, one complete rotation is 360 degrees. So for theta, let's say it's approximately 360 degrees, so all the way around. Then minus, you've got to take this part right here out, okay? So again, you can make a little right triangle and figure that out. So you can just call this angle beta if you want, or alpha, or whatever you want to do. Let's just say that for beta, well, this is going to be equal to the inverse tangent of, again, I'm just going to work with positive numbers because, again, if you plug in a negative here, you're going to get this going clockwise, and I just want this counterclockwise to make it simple. So what I'm going to do is say that the opposite here, instead of being negative 35, I'm just going to put 35, and the adjacent here would just be 12. So let's key this into the calculator. So I get about 71.08 degrees. So let's say this is approximately 71.08 degrees. And I'll just write that up here. You can actually get rid of it from here. And you could write it into your sketch if you want to. So this angle right here, we'll say it's about 71.08 degrees. You do your subtraction here. So 360 degrees, and that looks kind of terrible. So 360 degrees minus 71.08 degrees, you're going to get about 288.92 degrees. So let's grab this real quick and let's paste this in here. So coming down, it looks like I want this one. So the magnitude of my vector v is 37. The direction angle theta is about 288.92 degrees. All right, for question 3, we want to find the magnitude and direction angle for each vector. Now here we do not have this given in component form. So you have the vector AB, and basically to put it in component form, again, you want to go terminal minus initial. So we are told that B is the terminal point and A is the initial point. So for the horizontal component, just take this -2, subtract away 1, that would be -3. For the vertical component, just take this 5, subtract away 10. 5 minus 10 is going to be -5. So again, always think about this as terminal minus initial. Terminal minus initial. That's all you have to remember. So let's grab this real quick and let's come down here. Now, your book may rename it at this point. It might say, okay, this is the vector V or U or W. You're free to do that if you want, but I'm just going to work with it like this. So we'll see that here we're in quadrant 3, okay? So the magnitude of my vector AB is going to be equal to the square root of, you have -3 squared, which is 9, plus -5 squared, which is 25. We know that 9 plus 25 is 34. So this would just be the principal square root of 34, and you really can't do anything with that. So 34 is 17 times 2, and neither of those numbers are going to break down any further. All right, so now we have a direction angle that's going to be in quadrant 3. So let's say that this is my theta. Okay, so how do we figure this out? Well, we know that this angle right here, this piece of this, is 180 degrees. So let's say that theta is equal to 180 degrees. Now I just need to figure out what is this part right here, and I'm just going to add that. Let me put approximately here so I don't mess that up. I'm just going to add that in, right? So I need to figure out what is that part right there, and that's very simple to do. So let's just form a little right triangle, and maybe I'll make that a little bit better here. So let's make that angle like this. Let's just call this beta, okay? So you have your opposite, which in this case would be -5. Let's just use positive numbers. So we're going to say tangent of beta is equal to, instead of -5, let's use 5. And then the adjacent is, instead of -3, let's just use 3. It would divide out anyway because negative over negative is positive. But again, I'm just going to put it in as 5/3 and just work with the positive. Now, for beta, you would say this equals to the inverse tangent of this 5/3 here. Let me get rid of this. And if you key this into your calculator, I get about 59.04 degrees. So let's say this is about 59.04 degrees. Let's put that in here. So 59.04 degrees. So basically, all you need to do, again, is take this straight angle here, which is 180 degrees, and then add in this angle right here, which is going to be 59.04 degrees. Okay. If we punch this into our calculator, you're going to get about 239.04 degrees. So this is about 239.04 degrees. So let's grab this real quick, come back up and paste this in. And basically we're looking for the magnitude to be the square root of 34. And then, so we have that here, but that's not it. So we come down here, the magnitude of this vector AB is square root of 34. The direction angle theta is 239.04 degrees. So this is the guy that we want. All right, for question 4, we're asked to write each vector in component form given the magnitude and direction angle theta. We're also told to round to the nearest hundredth. Okay, so the formula for this is very simple. If you have your vector R, and you have the magnitude of that, and that's 60, and the direction angle theta is 49 degrees, well, if you want to find the component form of your vector R, this right here is going to be your magnitude of your vector R times the cosine of that direction angle theta. Okay, so that's the first part. The second part, let me slide this down, or actually, maybe I can just bring this to another page. and we'll come back up in a moment. This part right here is the magnitude of my vector r times the sine of my direction angle theta, right, which is 49 degrees. So let's just figure out what this is. So we know that this is 60 in each case. So let's just get rid of this and put 60 in here. Let's get rid of this and put 60 in here. And essentially, you're just going to key this into your calculator. So 60 times the cosine of 49 degrees. If I round to the nearest hundredth, I get 39 point, let's say 36. Let's put this as 39.36. And then here you have 60 times the sine of 49 degrees. And that's going to be about 45 point, let's say 28. So this is about 45.28. Okay, let's grab this and let's come back up here and I'll just paste this in up here. I think we can still see it. So for the component form of my vector r, I'm looking for 39.36 for the horizontal component and 45.28 for the vertical component. So that guy right there. All right, let's take a look at question 5. So here we want to write each vector in component form given the magnitude and direction angle theta. So here we have that the magnitude of our vector m is going to be 18. We have that the direction angle theta is going to be 315 degrees. Let's just grab this real quick and we'll just paste this in right here. So for the component form of the vector m, again, for the horizontal component, it's going to be the magnitude of that vector m, which is 18, then times the cosine of your direction angle theta. So the cosine of 315 degrees. Now, cosine is positive in quadrant 4, so you could really just think about this as the cosine of 45 degrees because that's the reference angle there. So the cosine of 45 degrees is square root of 2 over 2. So this is square root of 2 over 2. 18 divided by 2 is 9. So basically, this would be 9 times square root of 2. Okay, the other guy would be the magnitude of your vector m, which is, again, 18, and then times the sine of your direction angle theta, which, again, is 315 degrees. So here, the sine of 45 degrees, which is the reference angle, is square root of 2 over 2, but you're in quadrant 4, so sine is negative. So you want the negative of the square root of 2 over 2. So 18 divided by 2 is 9. So let's just say that this is negative 9 times the square root of 2. So this would be your component form. So let's grab this real quick, and we'll just come back up here. And so the horizontal component is 9 times square root of 2. And so you see that here, and then also here and here. And then the vertical component is negative 9 times square root of 2, so that's only going to be here. So this is going to be your component form for the vector m. Again, the horizontal component is 9 times square root of 2, and the vertical component is negative 9 times square root of 2. All right, let's take a look at the quiz. For the first question, we're asked to find, we have negative 9 times our vector a, and then plus our vector b. So to set this up, let's go negative 9, and then my vector a in component form. You've got a horizontal component of 6 and a vertical component of 10, and then plus the vector b. So you've got this in component form. So the horizontal component is negative 12, and the vertical component is 8. Okay, so all you really need to do here is multiply this negative 9 by each component here. So negative 9 times 6 would be negative 54. Let me move this out here so I can put my bracket there. And then negative 9 times 10 would be negative 90. And then you have plus this other guy here. So you have negative 12 and then 8 for the components. So as a last step, just add the horizontal components together. So negative 54 plus negative 12, that's going to be negative 66. And then negative 90 plus 8, that's going to be negative 82. Okay, so let me erase all of this. So this would be our, what we call resultant vector. Okay, so let's bring this up here. And so I'm looking for this negative 66 as the horizontal component and negative 82 as the vertical component. So this guy right there. All right, let's move on now and look at question 2. So now we want to find 5 times the vector u minus, or actually let me put plus negative. I think that's better. So plus negative 4 times the vector v. Okay, so looking at this guy, let's go ahead and set this up as 5 times the vector u in component form. The horizontal component is negative 12. The vertical component is negative 7. And then plus, I'm going to go negative 4 times this vector v. So this is in component form. So the horizontal component is 8, and the vertical component is 2. Okay, so let's set this up here. So 5 will be multiplied by each component here. 5 times negative 12 is negative 60. So let's say this is negative 60 here. And then 5 times negative 7 is negative 35. And then over here, negative 4 will be multiplied by each component. So negative 4 times 8 is negative 32. And then negative 4 times 2 would be negative 8. Okay, the last thing we're going to do is sum the horizontal components together. So negative 60 plus negative 32, that's going to be negative 92. And then if we sum the vertical components, negative 35 plus negative 8, that's going to give me negative 43. Okay, let me erase this, and I'll just drag this up here. And so looking through my answers, I want this guy right here, right? So the resultant vector, we'd have a horizontal component of negative 92 and a vertical component of negative 43. All right, let's take a look at question 3. So here we want to find 7 times the vector u, and then minus 10 times the vector v. So I'm going to convert this over and say this is plus negative here just to make it a little bit easier. So let's say this is equal to, you have 7 times the vector u. So in component form, the horizontal component is negative 7, the vertical component is negative 8. Then we're going to have plus this negative 10 times this vector v. So this is in component form, the horizontal component is negative 8, and the vertical component is 8. Okay, so what we'll do here is multiply the 7 by each component there. 7 times negative 7 is negative 49. And then 7 times negative 8 is negative 56. So then we have plus this guy right here. Negative 10 will multiply by each component. So negative 10 times negative 8 would be 80. And then negative 10 times 8 would be negative 80. Okay, so the last step here is just to sum the horizontal components. So negative 49 plus 80, that's going to be 31. And then negative 56 plus negative 80, that's going to be negative 136. So let me get rid of this. Let me scooch this up here. And looking through these guys, it looks like I want that one right there. So for the resultant vector, the horizontal component is 31, and the vertical component is negative 136. Okay, let's take a look at question 4. So we're asked to find the component form of the resultant vector. So we have negative 2 times the vector u plus 2 times the vector g. Now, we're not given u or g in component form, so what we have to do is create that. Now, depending on how accurate you want your answer, you can change up the way you do it. You can round and then work with that rounded value, or you can just round at the end. So I'm just going to round initially. It's probably going to be a little bit different for the answer, but it'll be close enough. So let's go ahead and say that, first and foremost, if we want the component form of the vector u, you're going to take the magnitude of u, which is 9, and multiply it by the cosine of the direction angle, which is 64 degrees. So that's your horizontal component. For the vertical component, you take that magnitude, which is 9, and then times the sine of that direction angle, which is 64 degrees. Okay, so that's the component form for your vector u, and I'll approximate that in a moment. And then for the vector g, let's do the same thing. So the magnitude is 6, and then times the cosine of the direction angle, which is 45 degrees. So we know that's square root of 2 over 2. So you could write that in now if you wanted to. So let's put square root of 2 over 2. And then this one would be 6 times, and the sine of 45 degrees would also be the square root of 2 over 2. So again, you can approximate this now, or you could work with these values in your calculator. But either way, it's going to be so close, you'll be able to figure out what the answer is. So I would just estimate this now and say that for the vector u, this is going to be about, and I'm putting equals here, but this is an approximation. So 9 times the cosine of 64 degrees, let's say that's going to be about 3.9, let's go 5. So 3.95. And then 9 times the sine of 64 degrees, let's say that's about 8.0, let's say 9. Okay. Then for this one, for the vector g in component form, this right here, so 6 divided by 2 would be 3. And this is going to be the same in each case. So this is 3 times square root of 2. You can approximate that if you want, or you can just leave it as is and approximate it later. I think maybe we'll just key it into the calculator. And I get about, let's say 4.24. So that's going to be the same in each case. So let's get rid of this. And let's slide this up here like this. And let's write down what we want. So negative 2 times the vector u, and then plus 2 times the vector g. So let me grab this real quick. Come back down here. Paste this in. Okay, this is a bit sideways, so let me rewrite it. So you'd have negative 2 times this vector here. So let's put this in here. So 3.95 and then 8.09. So those are the components. then plus 2 times this vector here. So it's 4.24, and then 4.24 again for the components. Okay, so negative 2 times 3.95, that's going to give you negative 7.9. And then negative 2 times 8.09, that's going to give you negative 16.18. Then over here you have plus 2 times 4.24, that's going to give me 8.48, and that's going to be the same over here. Okay, so now what I want to do is add the horizontal components together. So negative 7.9 plus 8.48, that's going to be 0.58. And then I want to do the same thing for the vertical components. So negative 16.18 plus 8.48, that's going to be negative 7.7. So let's grab this real quick. This would be our resultant vector. So let's paste this in here. And let me slide down a little bit so we can see our choices. So coming down here, do we see anything that's close? Well, yeah, it's going to be this one. Again, because of rounding, it's not going to be exact, but here you get 0.58, here you have 0.59, so that's extremely close. And here you have negative 7.69, here you have negative 7.7, so this is what we're looking for. You don't see anything else that's close to that, so just keep that in mind when you're solving these problems. They're created by a computer and they're solved by a computer, so their answer is going to be close to yours, but not exactly the same because of rounding. Okay, let's take a look at question 5. So again, we want to find the component form of the resultant vector. So here we want to find negative 5 times the vector f plus 3 times the vector g. So we are given that the magnitude of our vector f is going to be 3, and the direction angle, theta, is 177 degrees. So you can use that to get your component form. Again, just take your magnitude, which is 3, times the cosine of that direction angle, which is 177 degrees. That's the horizontal component. For the vertical component, it's going to be 3, that magnitude, times the sine of that direction angle, which is 177 degrees. So that's going to be your component form. Now, we'll estimate this in a moment. Let's go down here and set up vector g. We'll do the same thing. So here, the magnitude is 19, then times, we'll have the cosine of 120 degrees. So for this one, you could replace it with the exact value if you want, but I'm just going to key it into the calculator. We know that the cosine of 60 degrees is a half. So the cosine of 120 degrees, you have a 60-degree reference angle, it's going to be negative a half, right? Because you're in quadrant 2 and the reference angle is 60 degrees. So for over here, I'm just going to put 19 times the sine of 120 degrees. You know that that is square root of 3 over 2, but again, I'm just going to let the calculator take care of it. So let's grab that. And let's paste this in here. Let's key this into the calculator. And for this one, let's just say it's about negative 3. For this one, let's say that it's going to be about 0.16, just rounding to the nearest hundredth. Okay, so down here, this is basically 19 times negative 1/2, which is going to be negative 9.5. You can also just key that into your calculator if you want. Doesn't matter. Then here, this 19 times the sine of 120 degrees, it would be about, let's say 16 point, let's go for 5. So in each case I used equals. If you want to be more accurate, you can say it's approximately, but I'm just going to use equals. It's a little bit easier to work with. A lot of us are just self-studying, so it really doesn't matter. So now what I want to do is come back up here and say this is negative 5 times the vector f plus 3 times the vector g. So let me grab this real quick, and let's say this equals. So you'll have negative 5 times this vector here. So you've got negative 3, and then 0.16, those are your components. And then you're going to have plus 3 times this vector here. So you've got negative 9.5, and then you've got 16.45. Those are your components there. Okay, so let's say that we're going to multiply this negative 5 by each component here. So negative 5 times negative 3, that's going to be 15. And then negative 5 times 0.16, that is going to be negative 0.8. Let's close that down. So then plus, we're going to multiply 3 by each component here. 3 times negative 9.5, that is going to be negative 28.5. And then 3 times 16.45, that's going to be 49.35. So then here, we would add the horizontal components. So 15 plus negative 28.5, that's going to be negative 13.5. And then negative 0.8 plus 49.35, that's going to be 48.55. Okay, so this is the resultant vector. So just bringing this down here and looking through my choices, it looks like I want this one right here. Again, the answer is not exactly the same, and it's just because of rounding. when the computer does it, it's going to round at a different place. So it's going to throw things off just a little bit. So here you have negative 13.5 as your horizontal component for the resultant vector. Here you have negative 13.52. So very close. Here you have 48.55 for the vertical component of your resultant vector. And here you have 48.58. So again, very close. You don't have anything else that's even remotely near that. So this is the answer we want. All right, let's take a look at the quiz. For the first question, we're asked to find the unit vector u in the direction of v. So for this, we use a simple little formula. So I'm going to say my unit vector, so I put a little hat on top of the u, is going to be equal to, you're going to take your vector v, which right now is written as a linear combination. So let me actually change that. I'm just going to write it like this in component form. So negative 3 is the horizontal component. Again, it's what's multiplying the unit vector I. And then we're going to say negative 7 is the vertical component. It's what's multiplying the unit vector j. So this guy right here would be multiplied by 1 over the magnitude of this vector v. So for the magnitude, it's just the square root of, let me slide this down so we have enough room, like this. It's going to be this guy, this horizontal component squared. So negative 3 squared is 9. And then plus this vertical component squared. So negative 7 squared is 49. So what is 9 plus 49? That's going to be 58. So let me write that under there. Now 58 is 29 times 2, so you really can't do anything with that. So what I'm going to do is say this is equal to, and actually let me just grab this real quick. I think maybe that screen is a little bit too busy to write things on. So let's say that this is going to be the negative of 3 over the square root of 58. And then we're going to have the negative of 7 over the square root of 58. Now, typically, you would rationalize the denominator, but in some cases, the book that you're working with might not do it for these problems. So it's really up to you if you're self-studying. So I'm just going to come like this and say that I'm going to multiply by the square root of 58 over the square root of 58, like this. So this would be the negative of 3 times the square root of 58 over 58. Let me actually get rid of this from here. I think it's just in the way. And then here, we would multiply by, let me slide this down a little bit, square root of 58 over the square root of 58. So this would be the negative of 7 times the square root of 58 over 58. So let me get rid of this and just slide this back down. And this right here is what we're going to be looking for. So let me grab this real quick. So let me paste this in here. Now this is given as a linear combination of I and j. So what you want to do is just convert this over. So negative 3 times the square root of 58 over 58 times the unit vector I, and then minus you have 7 times the square root of 58, and then over 58 times the unit vector j. So you can get rid of this. Not going to need that anymore. So looking through my answers, it looks like I want this one right here. So you're going to have the negative of 3 times the square root of 58 over 58 times your unit vector I, then minus, you have 7 times the square root of 58 over 58 times your unit vector j. All right, for question 2, we're asked to find the dot product of the given vectors u and v. So we're going to say u dot v is equal to, you would multiply the horizontal components together. So 4 times 9 is 36. And then you would add that to, you would multiply your vertical components together. So be careful here, this is minus 4. So you want to take that negative with you. So you want to go negative 4 times 7, that's going to be negative 28. And so this would be equal to, 36 minus 28 is going to be 8. So coming down here, we want this one. That's going to be the dot product of the vectors u and v. All right, for question 3, we're asked to find the measure of the angle theta between the vectors u and v. So let me write this out. We have u, this vector here, is a linear combination. So we have negative 2 times the unit vector I, and then minus 2 times the unit vector j. And then we have the vector v, so also a linear combination. So we have 9 times the unit vector I, and then minus 4 times the unit vector j. Okay, let me grab this real quick, and let's paste this in. So hopefully you remember the formula at this point. Essentially what you're going to do is say that the cosine of theta is equal to the dot product of these two vectors. So u dot v. This is over the magnitude of your vector u times the magnitude of your vector v. All right, for the dot product, so we're going to go u dot v like this. We're going to multiply the horizontal components together. So negative 2 times 9 is negative 18. And then plus, we're going to multiply the vertical components together. Let me go plus negative and plus negative, just to make that more clear. So negative 2 times negative 4, that's going to be positive 8. So negative 18 plus 8, that's going to be negative 10. So this right here, I'll just replace it with a negative 10. Now, if we're looking to find the magnitude of our vector u, and that looks like a v, so let me make that more clean. This is the square root of, go up to u, so you want your horizontal component, which is -2 squared, and then plus your vertical component, which is also -2 squared. So -2 squared in each case is 4. 4 plus 4 is 8. So you would write that as 4 times 2, because 4 is a perfect square. So this is 2 times square root of 2. So 2 times square root of 2, let me erase this and put 2 times square root of 2. Okay. For the magnitude of the vector v now, what we're going to do is say that it's the square root of, you're going to take your horizontal component, which is 9 squared, that's 81. Then plus your vertical component, which is -4 squared, that's 16. 81 plus 16 is going to be 97. So let's write that in there. Let's get rid of this and say that this is times the square root of 97. Maybe that can be a little bit better there. Okay, let's get rid of this. Now, you can do this multiplication here now before you punch it into your calculator, make it a little bit easier. 2 times 97, that's going to be 194. So let's write this as 2 times the square root of 194 for the denominator here. So theta would be equal to the inverse cosine of this guy. So let's go the negative of 10 over 2 times the square root of 194. But let's just go ahead and cancel this out and put a 5 here. So you'd punch in the inverse cosine of -5 over the square root of 194. Now again, be very careful when you punch this into the calculator, otherwise you're going to get a domain error. So I get about, let's say 111 point, let's go 0.4 degrees. So let's grab this. So let me paste this in here. I'll just get rid of this. This is really all we need, this part right here, and drag this over. So theta is approximately 111.04 degrees. So this guy right here, that's going to be your approximate angle between the vectors u and v. All right, let's take a look at question 4. So we want to find the measure of the angle theta between the vectors u and v. Okay, so what we have here is our vector u, again, given as a linear combination. So -2 times the unit vector I minus 7 times the unit vector j. Let me go plus negative here. Then for the vector v, let's say this is 1 times the unit vector I, and then minus 4 times the unit vector j. Let me go plus negative here. And I put that 1 there just because we're going to need it when we find different things like the dot product or the magnitude. So let me come down here and just paste that in. So if you ever see a unit vector I by itself or a unit vector j by itself, just put a 1 out in front. Okay, so again, the formula, the cosine of theta is equal to the dot product of the vectors u and v over the magnitude of the vector u times the magnitude of the vector v. So what is this going to be? Let me write this over here. So we're going to go u dot v, and that's going to be, you take -2 and multiply by 1, that's -2. Then plus, you take -7, multiply by -4, that's going to be 28. So this is going to be -2 plus 28, which is 26. Let me get rid of this, and we'll say that this is 26. Okay, let's get rid of this. And let's find the magnitude of the vector u, and let's find the magnitude of the vector v. So this one is the square root of, you have -2 squared, which is 4, and then plus -7 squared, which is 49. 4 plus 49 is going to be 53. So this would be the square root of 53 for the magnitude of vector u. Then for the magnitude of the vector v, this is the square root of, take 1 and square it, that's 1, and then plus -4 squared is 16. So 1 plus 16 is 17. So this is the square root of 17. So you could write these down here, but what I'm going to do is just multiply them together. So square root of 53 times square root of 17, that would be the square root of 901. I just think it makes it easier when I key it into my calculator that way. This guy right here, when you plug it in, you get a lot of domain errors if you just mess up and don't put parentheses or something like that. So I try to keep it as simple as possible. So theta is equal to the inverse cosine of this guy right here. So 26 over the square root of 901. So let's key that into the calculator. So I'll say that this is about, let's go 29 point, and I'll go 98 degrees. Let me actually get rid of this because we're going to use this as our answer. Let me just slide this up here, and let's just grab this real quick, and we'll just paste this in here. So theta is about 29.98 degrees. Again, that's going to be my measure for the angle theta between the vectors u and v. All right, let's take a look at question 5. So now we want to determine b so that the two vectors u and v are orthogonal. So for the vector u, I'm going to say this is 1 times the unit vector I, and then plus b times the unit vector j. And then for the vector v, this is 3 times the unit vector I, plus 10 times the unit vector j. Okay, let me grab this real quick and let me paste this in here. So hopefully you remember that two vectors are going to be orthogonal if the angle between them is 90 degrees. So in other words, if the dot product is 0. When you look at that formula, the cosine of theta is equal to, you got u dot v like this, and this is over the magnitude of u times the magnitude of v. Okay, well, if this part is 0 and this is not 0, you get cosine of theta equals 0, and so theta would be 90 degrees, so you have orthogonal vectors. So in this particular case, we're not asked if we have orthogonal vectors. We're told, hey, find a value of b such that they're going to become orthogonal vectors. So all you really need to do here is say that u dot v is going to be equal to 0. So we'd have 1 times 3, just multiply the horizontal components, that's going to be 3. And then plus, you'd have b times 10, so that's 10b. And this, we want to have it equal to 0. So how do we do that? Let me write this over here. We're going to have 3 plus 10b is equal to 0. So just going back to basic algebra, we're going to subtract 3 away from each side. This cancels. You have 10b is equal to negative 3. Divide both sides by 10, and you get b is equal to negative 3 over 10. And you can see that would work. If you plugged in negative 3 over 10 there, well, basically you'd have negative 3. 3 plus negative 3 would be 0, so that would give you orthogonal vectors. So we're going to come back up and select that b is equal to negative 3 over 10. All right, let's take a look at the section quiz. For the first question, we're asked to find the component form. So here we're given this vector AB, and at this point, it's not in component form. So in other words, the initial point is not at the origin. Now, to put this in component form, all you have to do is set up terminal minus initial. So that's all you really have to remember. The A is going to be the initial point because it's listed first, and the B is the terminal point because it's listed second. So here, for the horizontal component, you want to go terminal minus initial with the x values. So B again is the terminal, the x value is 0, and then A is the initial, the x value is negative 2. So be very careful here because you want minus a negative 2. Let's put a comma in here. Now here's for the vertical component, and again, terminal minus initial. So now you're working with the y values. So 1 is the y value from the terminal, minus 8, which is the y value from the initial. So let's go ahead and say that 0 minus a negative 2 is 0 plus 2, so that's 2. And then 1 minus 8 is going to be negative 7. So thinking about this, let me get rid of this part right here, and I'm actually just going to slide this up like this. And I really messed up my notation there. So the vector AB, which a lot of books will rename it and call it maybe like the vector V or U or whatever at this point, but I'm just going to keep it simple. In component form, the horizontal component is 2, and the vertical component is negative 7. So we want to select this answer right here. All right, let's take a look at question 2. So we want to find the magnitude and direction angle theta for each vector. So here we have this vector RS. And again, it is not in component form. So the initial point is R and the terminal point is S. So to find the component form, again, all you have to do is go terminal minus initial. So for this point S here, the x-coordinate is 5. For this point R here, the x-coordinate is negative 2. So you're going to go 5 minus a negative 2. Let me write that out. So 5 minus a negative 2. And then here for the vertical component, you're going to go 5 again, because that's your y value here, minus 1, that's your y value here. So terminal minus initial. So 5 minus 1, let's close that down. So 5 minus a negative 2 is going to be 5 plus 2, so that's going to be 7. And then 5 minus 1 is going to be 4. So this is your component form for this vector RS. And again, if you want to rename it to something like the vector V or U or whatever, that's up to you. So let me actually make this a little bit cleaner here. I'm going to take this real quick and bring this over here. The first thing is we want to find the magnitude of this vector RS here. So to do that, it's just the principal square root of the horizontal component squared, so 7 squared is 49, and then plus the vertical component squared, so 4 squared is 16. So what is 49 plus 16? Well, that's going to be 65. So the magnitude of this vector RS is going to be the square root of 65. Now let's talk about the direction angle. Essentially, all you have to do is say that the tangent of theta is equal to, you're going to take your vertical component, which is 4, and put that over your horizontal component, which is 7. Now, because this guy would be in quadrant 1, you can just use your inverse tangent function. So you could say tangent inverse of 4 over 7. That would be your theta. So let me move this over here and say that theta is equal to this, which is approximately, let's key that into the calculator. I get about 74 degrees. Let's write that out. So 29.74 degrees. So I'm just going to copy these two guys right here, and let me paste this in here. And looking through my choices, actually this is kind of a mess here, so let me slide this over. And I'm just going to come down here so things fit on the screen. So this one has square root of 65, but the direction angle is wrong. This one has square root of 65, but the direction angle is wrong. So this is the one we're going to want. So the magnitude of my vector RS is the square root of 65, and my direction angle theta is going to be about 29.74 degrees. All right, let's take a look at question 3. So here we want to find the magnitude and direction angle theta for each vector. So we're given that the vector M has a horizontal component of -2 and a vertical component of 2. So this is given to us in our component form. Let's grab this real quick, and I'm going to paste this in. You'll notice that I have a coordinate plane that's on the page here because the direction angle is going to be a little bit more complicated. So let's start out with the magnitude of this vector M. It's very straightforward. So it's the principal square root of, take your horizontal component, which is -2, and square that, and then plus your vertical component, which is 2, and square that. So this becomes the square root of, -2 squared is 4, and then 2 squared is also 4. So this is the square root of, 4 plus 4 is 8. So this becomes the square root of, 8 is 4 times 2, and then this becomes 2 times square root of 2. Right? Because 4 is basically a perfect square. So the square root of 4 is 2, so you can bring that outside. Let's get rid of all this, and let's drag this up here. Okay, don't need two equal signs, so let me fix that real quick. Now, when we think about the direction angle, remember you can say that the tangent of theta is equal to the vertical component, which is 2, over the horizontal component, which is -2. So 2 over -2 is -1. But the problem here is if you use your inverse tangent function, you're not going to get the correct answer. So we know this would give us -45 degrees because of how the inverse tangent function works. If you plug in something that's positive, so let's say you did +1, you're going to get that angle in quadrant 1. If you plug in something that's negative, you're going to get that angle in quadrant 4, and you're rotating clockwise. So let's sketch this vector, and then let's think about how we can use this information here to get the correct result. The terminal point is going to be at 2 units to the left and 2 units up, so -2, 2. So this is -2, 2. And let's go ahead and sketch that vector. So that's what you would look like. Now, if I think about this angle here, and I'm not going to draw a vector, I'm just going to draw a simple little angle sketch. What's happening is the inverse tangent function is giving us this angle right here, which is -45 degrees, right? If you found the coterminal angle, it would be 315 degrees, but let's just work with this. What do I need to do to get myself to this guy right here? So keep in mind that this angle would be this guy right here. So that's what I want. That's going to be my theta. Well, what's going to happen is I need to start here, and I need to add a straight angle, or this guy right here, which is going to be, let me use a different color here, 180 degrees. So that's all I need to do. I need to take this -45 degrees, which is what I found, that's where I am right there, and add 180 degrees to that to get to my correct direction angle theta. So let me get rid of all of this, and let me just say that we're going to have theta is equal to -45 degrees, so that's what we found from the inverse tangent function, then plus, I'm going to correct that, so I'm going to add a straight angle there, or 180 degrees, and that's going to give me my correct value for theta. So let me get rid of this right here. So this is crystal clear. We're finding theta. And so this is going to be equal to 135 degrees. Okay, let me get rid of this and scooch this up here. And you can think about this whole thing right here. Let's say you thought about this angle right here. That would be 180 degrees. Then this piece right here, if you went through and figured it out, that would be 45 degrees, right? So you know that 180 degrees minus 45 degrees would also give you 135 degrees. So that's another way you could have done this. Either way, let's go ahead and grab this now, and let's paste this in. Let me slide down so these answers fit here. We're looking for a magnitude, which is 2 times square root of 2, and then a direction angle theta, which is 135 degrees. So this is what we're looking for right there. All right, for question 4, we're asked to write each vector in component form given the magnitude and direction angle theta. So we have that the magnitude of this vector b is equal to 84, and that the direction angle theta is equal to 315 degrees. Let's grab this real quick, and we'll just come to a fresh sheet. So hopefully you remember this. If I'm trying to find the component form of this vector b, then what's going to happen is, for the horizontal component, you want the magnitude of that vector, which is 84, and then times the cosine of the direction angle, which is 315 degrees. Now, cosine is positive in quadrant 4, and this has a 45-degree reference angle. So basically, the cosine of 45 degrees is square root of 2 over 2, and so the cosine of 315 degrees would be square root of 2 over 2. Now, 84 divided by 2, that's going to be 42, so let's just say that this is 42 times the square root of 2. Now over here for the vertical component, you're going to take that magnitude, which is 84, and now it's times the sine of 315 degrees. Well, sine is negative in quadrant 4, but again, you have a 45-degree reference angle, so the sine of 45 degrees is square root of 2 over 2, but again, you'd want to make this negative because you're in quadrant 4. Let me get rid of this and put negative square root of 2 over 2. So again, 84 divided by 2 would give you 42. So basically, this is negative 42 times your square root of 2. So this is your component form. Pretty easy in this case. Let's go ahead and grab this real quick. So let's paste this in right there. So looking through the choices, looks like we want this one right here. So for the vector b, given in component form, the horizontal component is 42 times square root of 2, and the vertical component is negative 42 times square root of 2. Okay, for question 5, we want to write each vector in component form given the magnitude and direction angle theta. So here we have the magnitude of our vector v. This is going to be 36, and the direction angle theta is going to be 210 degrees. So once again, for the component form of the vector v, the horizontal component is the magnitude of that vector v, which is 36, times the cosine of that direction angle, which is 210 degrees. Now, 210 degrees is in quadrant 3, so that means that cosine is negative. So I'm going to put that this is the negative of, now you have the cosine of, the reference angle there would be 30 degrees, okay? So the cosine of 30 degrees, that's going to be square root of 3 over 2. So this ends up being the negative of the square root of 3 over 2. Now, if we think about 36 divided by 2, that's 18. So let's just go ahead and say that this is going to be negative 18 times the square root of 3. Okay. Over here, again, it's the magnitude of that vector v, so that's 36, and then times, now it would be the sine of this angle, which is 210 degrees. So sine is also negative in quadrant 3. So let's go ahead and say that I'm going to put a negative out in front here, and then I'm just going to say this is 30 degrees here because that's the reference angle, and the sine of 30 degrees is a half. So basically you have negative 36 divided by 2, or times a half if you want to do it that way. That's just going to be negative 18. Okay, so pretty easy overall. Let's just grab this real quick. So looking through my choices, I want this one right here. So in component form, our vector v has a horizontal component of negative 18 times the square root of 3, and then a vertical component of negative 18. All right, let's take a look at question 6. So here, we're given the magnitude of this vector AB, and that's going to be 7. And we have a note here for the vector AB, the initial point is A, and the terminal point is B. So that's going to be important. So here, we have that for the initial point A, the coordinates here, you have negative 1 for the x value, and then 2 for the y value. And then for B, that point there, the coordinates, you have 4 for the x value, and then here's the tricky part, you have C for the y value. So what we're trying to find is, what are the possible values for C? So let me write this out here, that the magnitude of the vector AB, let me do that like that, is going to be 7. Okay, let me grab all this and come to a fresh sheet here, and let's think about this for a moment. So first off, what information are we given? We are given the point A and the point B and the magnitude of the vector AB. Now, I can set up an equation because I know that the magnitude of the vector AB comes from what? Well, you could put this in component form, and if you did that, you would come up with what? So the vector AB in component form is going to be 4 minus a negative 1, again, terminal minus initial, and then here it's going to be C minus 2. Okay, so 4 minus a negative 1, let's just replace that with 4 plus 1, which is 5. So we know that the magnitude of the vector AB is given to us as the square root of 5 squared, which is 25, and then plus this C minus 2 squared. Now I know that this is 7, so I'm just going to replace this with 7. Okay, let me get rid of this. And actually, you can get rid of all of this at this point. You don't need any of this information anymore. Just dump it. Now what we have is just a basic equation that we can solve for C. So that's the goal. So this guy right there. Now, the first thing I would do is square both sides. So this right here is going to get squared, and this is going to get squared. So this gives me, and I'm going to actually flip this around, 25 plus your C minus 2, so this is quantity squared, is equal to 49. Now, here's where a lot of people are going to make a mistake. Remember, you have to expand this. We haven't done this in a while because we haven't really been in algebra for a while, but it's a common mistake to not expand this, but you have to expand it. So basically, you would have C squared, and then you have minus 2 times C times 2. So 2 times 2 is 4, and then times C, that's 4C. And then plus 2 squared is 4. So I'm just using my formula. And then you have plus 25, and this equals 49. So what I'm going to do is go 4 plus 25, that's going to be 29. Let's go ahead and do that real quick. And now I can just subtract 49 away from each side. So 29 minus 49, that's going to be negative 20. So let me write minus 20, and this is going to be equal to 0. Now, can you solve this using factoring? No, because you're not going to have two integers such that the sum is negative 4 and the product is negative 20. So what we have to do is go into our quadratic formula. So here, let's say that A is 1. Let's say that B is going to be negative 4. And let's say that C is going to be negative 20. So I know this is a little bit confusing because you have a C in the problem. So if you want, you could temporarily change this to X and then just swap it back to C, just so you don't get confused, because this C right here is negative 20, but we're trying to solve for a C. So let's just go ahead and swap it with X, and we'll swap it back. So let's say that X is equal to the negative of B plus or minus the square root of B squared minus 4AC all over 2A. So I'm just going to plug in. So for the negative of B, so B is negative 4, so it's the negative of negative 4, and then B squared. So negative 4 squared, you could write that in, or you could just say it's 16. And then 4 times A times C. So A is 1, just get rid of it, and C is negative 20. So let's put plus negative here, and let's put negative 20 there. And then down here, 2 times A is 1, so you can just get rid of that. Okay, let's come down here, and we get X is equal to the negative of negative 4, that's going to be 4. And then plus or minus the square root of. So negative 4 times negative 20, that's 80. 80 plus 16 is 96. Let's try to simplify that real quick. So 96, if you go through and factor it, you can get it down to 16 times 6. And 16 is a perfect square. So the square root of 16 is 4. So you can say that this is 4 times the square root of 6 like this. Then this is over 2. Okay, so what I'm going to do to finish this up, I'm going to say X is equal to, factor out a 2 from the numerator. You're going to have 2 plus or minus 2 times square root of 6, and this is over 2. Let's cancel a common factor of 2 between numerator and denominator, and we're going to have X is equal to 2 plus or minus 2 times the square root of 6. Now, we said that we were going to replace C with X to make this a little bit easier. Let me just grab this real quick, and I'm just going to come back up here. And again, I'm just going to replace this X with C. This is just something we did because with a quadratic formula, you're working with A, B, and C, so it gets a little confusing. So for this guy, you'll see that for the possible values of C, you could have C being 2 plus 2 times square root of 6, or C could be 2 minus 2 times square root of 6. And you can pause the video and check those guys right there, and you'll see that you do in fact get a magnitude for the vector AB of 7 in each case. So let's come down here. Looks like we want this answer. So for C, it could be 2 plus 2 times square root of 6, or it could be 2 minus 2 times square root of 6. All right, let's take a look at question 7. So here we want to find 2 times the vector U minus 5 times the vector G. So this is pretty easy to do. I'm just going to write 2 out in front of my vector U. So the components are 9 and negative 10. Let me make this angle bracket a little bit better here. And then minus, you have 5 times this vector G. So the components are 9 and then 9. Okay, so you can always go plus negative if that's a little bit better for you. It's really just personal preference. I like it better. So here I'm just going to multiply this 2 by each guy here. So that would give me 2 times 9 is 18. And then 2 times negative 10, that's negative 20. And then here I'm going to multiply negative 5 by each guy. So negative 5 times 9 is negative 45. So that's going to be here and then again here. Okay, let me slide this down here so it fits on the screen. And I'll say this is equal to, so now all you have to do is add the horizontal components together. So 18 plus negative 45, that's going to be negative 27. And then you're going to add the vertical components together. So negative 20 plus negative 45, that's going to be negative 65. So this right here would be your resultant vector, or some people just say the resultant. And that's for 2 times the vector U minus 5 times the vector G. Let me get rid of this, and we can write that in. So 2 times the vector U, and then minus 5 times the vector G. So this equals this. So looking through my choices, this is the guy that I want. So for the resultant vector in component form, the horizontal component is negative 27, and the vertical component is negative 65. All right, let's take a look at question 8. So here we're trying to find 5 times the vector F plus 6 times the vector V. So again, just take 5 and put it out in front of your vector F. So the components, you have 5 and then negative 3. And then you're going to have plus, put a 6 out in front of your vector V. So you're going to have negative 3 and 7 as the components. So very easy to do this. Basically multiply 5 by each component here. 5 times 5 is 25. And then 5 times negative 3 is negative 15. And then plus, you have 6 multiplied by each component here. 6 times negative 3 is negative 18. And then 6 times 7 is 42. Okay, so now we're going to add the horizontal components together. So 25 plus negative 18, that's going to be 7. And then negative 15 plus 42, that's going to be 27. So this right here would be the resultant, or again, you can say the resultant vector. And let me put this up here. Maybe this could be a little bit better. And I'll say that this is 5 times the vector F, and then plus 6 times the vector V. So looking through my choices, looks like the first one is what I want. So for this resultant vector in component form, the horizontal component is 7, and the vertical component is 27. All right, let's take a look at question 9. So here, we want to find 8 times the vector Tx, and then plus 7 times the vector YZ. Okay, let me actually cut this away, paste this in here real quick. And what I'm going to do is find the vector Tx in component form. So again, you're going to go terminal minus initial. That's all you have to remember, terminal minus initial. So looking at this guy, we know that terminal is x and the initial is t. So 4 minus a negative 3. 4 minus a negative 3. And then over here, you say negative 5 minus a negative 7. So negative 5 minus a negative 7. So again, terminal minus initial. 4 minus a negative 3 is 4 plus 3, so that's going to be 7. And then negative 5 minus a negative 7 is negative 5 plus 7, so that's going to be 2. So let's put a 2 here, like this. Okay, let's also do this with the vector YZ. So in component form, again, terminal minus initial. So you're going to go negative 2 minus a negative 9. Negative 2 minus a negative 9. And then terminal minus initial. So you're going to go 1 minus 6. So 1 minus 6. So negative 2 minus a negative 9 is negative 2 plus 9. So that is positive 7. And then 1 minus 6 is going to be negative 5. So this is negative 5. Okay, let me grab this real quick. All right, so now that we have this guy, let's go ahead and say this equals. I'm going to put 8 times this vector Tx. So I'm going to put this in as 7 and 2 for the components. Let me actually rearrange this. I'm going to drag this down here and just slide down a little bit. So then this is plus 7 times this vector here. So the components, you have 7 and then negative 5. Okay, let's come down here a little bit. So basically, 8 is multiplied by 7. That's going to give me 56. And then 8 is multiplied by 2. That's going to give me 16. And then plus 7 is multiplied by 7. That's going to give me 49. And then 7 is multiplied by negative 5. That's going to be negative 35. Okay, so now that we've done that, again, all you're doing is adding the horizontal components. So 56 plus 49, that's going to give me 105. And then you're going to add the vertical components. So 16 plus negative 35, that's going to be negative 19. Let's paste this in. So this is our resultant. And we'll say that this is 8 times the vector tx plus, let me slide this down so it fits. Kind of a lot to write. So plus, and maybe I'll do that in a different color here. We'll say that it's going to be 7 times the vector yz. Okay, let me move this up here like this, and we're looking for this answer here. So it looks like this is what we want. So for the resultant in component form, it's going to have a horizontal component of 105 and a vertical component of negative 19. Okay, let's take a look at question 10. So here we're asked to find the component form of the resultant vector. So we want to find negative 5 times the vector A, and then plus 7 times the vector B. Okay, so the issue here is we're given the magnitude of the vector A in the direction angle, and then the magnitude of the vector B in the direction angle. So we have to come up with the component form for the vector A and the component form for the vector B. So let's actually start out with that. So let's say that we have the magnitude of the vector A, this is 9, and then the direction angle theta is 213 degrees. Let me actually grab this real quick and paste this in. So hopefully you know how this works at this point. The vector A in component form, again, for the horizontal component, just take that magnitude, which is 9, and multiply by the cosine of the direction angle, which is 213 degrees. And then here, for the vertical component, again, take the magnitude, which is 9, and then times the sine of the direction angle, which again is 213 degrees. So really easy to remember that. Let me actually get rid of this. And I'm going to do both of these at the same time. So let me move this down here. And let me come up here. The other guy, we had a magnitude for the vector B. This is 9. And then the theta here is 150 degrees. And I'm actually going to grab all of this at this point. So let me paste this in right here. And I'm just going to slide this down just a little bit. Okay. So for the vector B in component form, this now is going to be the magnitude is also 9, and then times now the cosine of 150 degrees. Now we know that this is negative square root of 3 over 2, so you could put that in now if you want. I'm just going to let the calculator deal with it, so don't even worry about it. Over here, this would be 9, which is the magnitude, times the sine of 150 degrees. Again, you could replace that with 1/2 if you wanted to, but I'm just going to leave it. Okay, let me get rid of this. And let's think about this for a moment. Let me get this up here like this. You have a negative 5, which is your scalar. So it's multiplying your vector A. So what you could do, you could put a negative 5 in here, and then put your 7, which is multiplying your vector B. So you could do that here and here. So let me actually get rid of this, and let me drag this up here. I know this is a lot of rearranging. Let's put this up here like this. So maybe I'll just say that this is negative 5 times this, and then I'll go plus 7 times this. And the reason I'm doing this is so that we can maybe do this in one shot and get a more accurate answer. I think it's going to be off either way, but I haven't actually checked it this way. So let's go through and look at what we have here. So negative 5 would multiply this. So that would be negative 45. Let me slide this down here. So this would be negative 45. And then negative 5 would multiply this. So again, this is also negative 45, like that. Let me put that there. So then this guy right here, so 7 would multiply by 9, and then 9 again. So in each case, that would be 63. So let's put 63 there, and then let's put 63 there. What you could do is key this into your calculator. So you could say negative 45 times the cosine of 213 degrees, plus 63 times the cosine of 150 degrees. So let's see what that gives us. So I get about negative 16, let's say let's go 82. So that's rounding to the nearest hundredth. Now you could put approximately here, or you could just keep it as equals. I'm just going to keep it as equals just to keep it a little bit simpler here, but we know this is an estimate here. Okay, let's put a comma. So I'm going to do the same thing here. So basically, I'm going to key this into my calculator. So negative 45 times the sine of 213 degrees, then plus 63 times the sine of 150 degrees. And if I stay consistent with what I just did, let's say that I'm rounding to the nearest hundredth. So this is about 56.01. So let's close this down. So this will match our answer exactly. Depending on what you do when you're rounding these types of problems, you might get a slightly different answer. So it's really okay. Just remember, you're getting an approximation here. So you're just looking for something that's very close, but it does not have to always be perfect. So let's say that this is going to be my negative 5 times my vector A, and then plus 7 times my vector B. So looking through my choices, let me slide down here a little bit so we can see. Looks like this is the one that we want. So the resultant vector in component form, the horizontal component is negative 16.82, and the vertical component is 56.01. All right, let's take a look at question 11. So we want to find the unit vector u in the opposite direction of f. So we have a little hint here. What does it mean to go in the opposite direction? We'll think about that in a moment. So we have this vector f, and it's written as a linear combination of the unit vectors I and j. So this is negative 27 times the unit vector I, and then minus 36 times the unit vector j. So let's grab this real quick, and let's paste this in right here. So if I was looking for a unit vector u, so you go u hat like this, in the direction of the vector f, all you really have to do, and I'm just going to write this in component form to make it a little bit cleaner. Let me write this vector f here. So this is negative 27 for the horizontal component. So that's what's multiplying this unit vector I, and then negative 36 for the vertical component. That's what's multiplying this unit vector j. You can go plus negative if that's not clear. Okay. So again, getting back to what I was saying, for the unit vector u, you're basically going to scale this guy down such that it has the same direction, but the magnitude is now going to be 1. So the typical formula is going to be your vector f is going to be multiplied by 1 over the magnitude of your vector f. So this 1 over the magnitude of the vector f, that's your scalar. Now, in this particular case, we don't want it in the same direction, right? We want it in the opposite direction. So for the opposite direction, you just have to multiply by negative 1. So what I'll do is just put this negative up here, and that's all you have to do. Okay, so this is our formula. So let's just go ahead and replace some things. I'll just slide this down like this. So first, I'm going to start with this guy in component form. So we have negative 27 as the horizontal component, and then negative 36 as the vertical component. Let me get rid of this. And this is times, we're going to have negative 1 over the magnitude of the vector f. So what is the magnitude of the vector f? Well, I'm just going to take the square root of negative 27, which is my horizontal component squared, and then plus negative 36, which is my vertical component squared. Now, I'm just going to punch this into the calculator, and it's going to give me 45. So this right here is going to be 45. So now all I have to do is multiply this by each component here, and basically I'll be good. So we'll have the unit vector u is equal to, you're going to have negative 27 over, basically think about this as me putting the negative down here. I think it's going to make it a little bit easier. So this is just over negative 45. And each here is going to be divisible by negative 9. So just go ahead and cancel the negatives out. And then 27 divided by 9 would be 3. And then 45 divided by 9 would be 5. So this would be 3/5 here for the horizontal component. Then for this guy, you'd have negative 36 over negative 45. So again, the negatives are going to cancel. And with 36 and 45, you're going to have a common factor of 9. So 36 divided by 9 is 4. 45 divided by 9 is 5. So your vertical component here would be 4/5. Okay, let me grab this real quick. All right, now I would note that the answers are given as a linear combination, and typically that's the case. If you get your vector as a linear combination, you want to answer as a linear combination. So for my unit vector u, it's going to be equal to 3/5 times the unit vector I plus 4/5 times the unit vector j. So remember, this is going in the opposite direction if you check things. So looking through my choices, looks like I want this guy right here. So again, 3/5 times the unit vector I plus 4/5 times the unit vector j. All right, for question 12, we're asked to find the dot product of the given vectors. So we have our vector u, which equals -3 times the unit vector I. And let's just put plus 0 times the unit vector j. Then we have our vector v, which is going to be -4 times the unit vector I. And then minus, or you can go plus negative if you want. This is going to be 3 times the unit vector j. So for the dot product, it's the vector u dot the vector v. This equals, you're going to multiply the horizontal components together. So -3 times -4 would be 12. And then plus, you're going to multiply the vertical components together. But this one is 0, right? So 0 times -3 is 0. So this is 0 here. So this is just going to be 12. So that's what I'm looking for the answer. All right, let's take a look at question 13. So we want to find the measure of the angle theta between the two vectors. So first off, we know that the cosine of theta is equal to, you're going to have the dot product of those vectors. So you're going to have vector u dot vector v over, you're going to have the magnitude of the vector u, and then times the magnitude of the vector v. So let's see if we can figure this out. So what is u dot v? Well, again, you're going to multiply the horizontal components. So this negative multiplied by the unit vector I, just treat that negative as -1. So you'd have -1 times -6, that's going to be 6. And then plus. This, you can think about that as a -7 and then times a 3. So you're multiplying the vertical components together. So that would give you -21. So let's just write -21 here. So 6 minus 21, that's going to give me -15. So let me replace this with -15. Okay, now we need to figure out what is the magnitude of the vector u. So this is the square root of, again, take your horizontal component, which is -1, and square that. Then plus, take your vertical component, which is -7, and square that. -1 squared is 1. And then -7 squared is 49. So this would be 1 plus 49, or 50, right? So the square root of 50, you could really say that that's 25 times 2. So let's go ahead and say this is 25 times 2. Square root of 25 is 5. So this right here would be 5 times square root of 2. Let's get rid of this and put 5 times square root of 2. Okay. What about the magnitude of the vector v? So again, the square root of, you're going to have the horizontal component, which is -6 squared, and then plus the vertical component, which is 3 squared. So that's going to be -6 squared is 36, and then 3 squared is 9. So 36 plus 9, that's going to be 45. Now 45 is going to be 9 times 5, and 9 is 3 times 3. So let's say that this is 3 times square root of 5. Okay, get rid of this, put times 3 times square root of 5. So let me get rid of this. Now, you would notice that you could do some canceling here, right? So with 15, 15 divided by 5 would be 3, and 3 divided by 3 would be 1. So really, I can get rid of this, and get rid of this, and get rid of this, and say that this is -1 over square root of 2 times square root of 5 is just square root of 10. Okay, so let's key this into the calculator. We'll say theta is equal to the inverse cosine of -1 over the square root of 10. So this is approximately, again, make sure you wrap these things in your calculator. Otherwise, you're going to get a domain error. Some calculators might not require that, but mine does. So I get about 108, let's say 0.43 degrees. If I round to the nearest hundredth, let's say this guy right there. All right, let's take a look at question 14. So here we're asked to state if the two vectors are orthogonal. So that means they meet at 90-degree angles, or you could say they're perpendicular, or you could also say the angle between them is 90 degrees. So essentially what you do is you look at the dot product of u and v. So u dot v, and you're trying to see, is that equal to 0? If it is, you're going to end up with the angle between them. Again, you would get cosine of theta is equal to 0, and so theta there would be 90 degrees. Okay, so let's just do the dot product. So here, let's first write out this vector u, and let me do that a little bit more cleanly. This is -4 times the unit vector I plus 2 times the unit vector j. Then for the vector v, this is what? We don't have anything multiplying the unit vector I. So I'm going to put a 0 there. So 0 times the unit vector I, and then plus 24 times the unit vector j. So again, you start with your horizontal components being multiplied together. So negative 4 times 0 is 0. And then plus your vertical components being multiplied together. So 2 times 24 is 48. So this is 48. It's not 0, so these guys are not going to be orthogonal vectors. So not orthogonal. All right, let's take a look at question 15 now. So we want to determine b so that the two vectors u and v are orthogonal. So again, that tells us that the dot product of u and v, so u dot v like this, would be equal to 0. So right now, it would be b, which is the horizontal component here, times 10, which is the horizontal component there, so 10 times b, and then basically plus your vertical component here, which is 2, times your vertical component here, which is 25. So let's just go ahead and say this is 10b plus 2 times 25 is 50. So what I want to do is figure out what is the value of b such that 10b plus 50 is equal to 0. Let me actually get rid of this. And I'll subtract 50 away from each side. So 10b would be equal to negative 50. And so just divide both sides by 10. And this is going to cancel. You get b is equal to negative 50 over 10. That's just going to be negative 5. So looking through my answers, I want this guy right here. So b equals negative 5. Again, all we're saying here is that if b was negative 5, these guys would be orthogonal vectors. So if you had this vector u, and this was negative 5 times the unit vector I plus 2 times the unit vector j. Let me make that a little bit better there. And then the vector v, let's say that was 10 times the unit vector I, and then plus 25 times the unit vector j. Well, now if we find the dot product, so u dot v, this is going to be what? Negative 5 times 10 is negative 50, and then plus 2 times 25 is 50. So this is 0. Right? So in your formula for the angle between two vectors, you would have the cosine of theta is equal to, you would get 0 over something that's not 0. So this is 0. So this tells me that theta is equal to 90 degrees. So that tells me the vectors are going to be orthogonal vectors. So here, to get that, b would need to be equal to negative 5. All right, let's take a look at the quiz. For question 1, we're asked to simplify each. So we have negative 3 plus, you have negative 6 plus 2i. And here we have this minus. I'm going to change this to a plus, and I'm going to distribute a negative to each guy there. So instead of a negative 1, I'm going to put a 1. And instead of a negative 3i, I'm going to say this is plus 3i. So you can always do that when you have subtraction. Basically, I'm changing this to plus and then putting a negative 1 there and distributing that to each guy. So at this point, I'm just going to combine what I can. Negative 3 plus negative 6, that's negative 9. And then negative 9 plus 1 is going to be negative 8. Then we have 2i plus 3i, that's going to be plus 5i. So this is in the form of a plus bi, so negative 8 plus 5i, so this guy right there. All right, let's take a look at question 2. We're asked to simplify each. So for this guy, I'm going to start with these first two. Negative 8 times 7, that's going to be negative 56. And then negative 8 times 8i, that's going to be minus 64i. And then 2i times 7, that's going to be plus 14i. And then 2i times 8i, that's going to be plus 16i squared. So I squared, we know that's negative 1. So let me just write minus 16 there. So negative 56 minus 16, that's going to be negative 72. Let's put that there. And then negative 64i plus 14i, that's going to be minus 50i, like this. Okay, so that's the first part. So now I'm going to multiply this by negative 6 minus I. Okay, so we'll say negative 72 times negative 6. That's going to be 432. Then negative 72 times negative I. Let's say that's plus 72i. Negative 50i times negative 6. That's going to be plus 300i. And then negative 50i times negative I. That's going to be plus 50i squared. Okay, so this right here, we know is negative 1. So let's just write a minus 50 there. So 432 minus 50, that's going to be 382. So let's put 382 here. Let's get rid of this from here. 72i plus 300i would be 372i. So 372i. So I'm looking for 382 plus 372i, so this guy right there. All right, let's take a look at question 3. So here we're asked to simplify each. So we have negative 9 minus 3i over 1 plus 7i. So what we're going to do here, let me just wrap these for clarity. I'm going to multiply the numerator and denominator by the complex conjugate of the denominator. So 1 minus 7i. All you're doing is you're taking the 1 and you're taking the 7i, then just change this from a plus to a minus. So this is 1 minus 7i here as well. So this is just a complex form of 1. So now we would say that negative 9 times 1, that's negative 9. Then negative 9 times negative 7i, that's plus 63i. Then negative 3i times 1, that's minus 3i. Let me make that 3 a little bit better there. And then negative 3i times negative 7i, that's plus 21i squared. So 63i minus 3i, that would be 60i. Let me get rid of that. And then this right here, you could write as a minus because I squared is negative 1. So negative 9 minus 21, that's going to be negative 30. So this right here is negative 30 plus 60i. Okay, then this is over. Down here, all you have to do is square the first guy. So 1 squared is 1. And then you're going to go plus. You're going to take this 7 here, and you're going to square that. So 7 squared would be 49. 1 plus 49 is 50. Okay, what I'm going to do is break this up. So it's in the format of a plus bi. Let me get rid of this real quick and drag this up here so we have some room. And so I'll say that this is negative 30 over 50. Might as well just say that's negative 3/5. So this is negative 3/5. And then plus, for 60 over 50, you could say that's 6/5 and then times I. So a plus bi. So I'm looking for negative 3/5 plus 6/5 I. So this guy right there. All right, let's take a look at question 4. We're asked to simplify each. We have I raised to the power of negative 307. Now, I say here that you can use a fast method or a slow method, and we talked about this in the lesson. So I'm just going to use the faster method here. And basically, I'm going to think about 307 and just going up, what number would be divisible by 4? Well, it would be 308. So this, I would multiply by I to the power of 308. And so this would give me I basically to the first power, or just I, okay? Now, why does this work? Well, if you think about 308, if you divide it by 4, it's 77. So you could really say this is I to the 4th power raised to the power of 77. Now, this is 1 raised to the power of 77, which is just 1. So all I did was I multiplied by a complex form of 1. And so when I used my rules for exponents here, I stays the same. You do 308 minus 307, that gives you 1. So you're left with I to the 1st power, or just I. And so that's the answer that I want. All right, let's take a look at question 5. So here we're asked to find the absolute value. So we want to find the absolute value of negative 14 minus 7i. And again, for this, it's just going to be the square root of, you take this guy right here, which is your a, so negative 14, and you square that. And then plus, you take this guy right here, which is your b. You can write plus a negative if you need to. Maybe I can make that a little bit better. So plus negative 7i like that. Just take the negative 7. So negative 7, and that's going to be squared. Okay, so this would be what? Negative 14 squared, that's 196. Negative 7 squared is 49. 196 plus 49 is 245. So this would be the square root of 245. Now, this would break up into 5 times 49, and the square root of 49 is 7. So you can go ahead and say that this is 7 times the square root of 5. So this is the answer we want. The absolute value of negative 14 minus 7i is going to be 7 times the square root of 5. All right, let's take a look at the quiz. For the first question, we're asked to write each in rectangular form. I want you to remember that rectangular form is also called standard form. So with a complex number, that's a plus bi, or you could do x plus yi. So here we have 4 times. In our parentheses, we're going to have the cosine of 330 degrees, and then plus I, that's your imaginary unit, then times the sine of 330 degrees. Let me copy this real quick, and let's just paste this in here. Okay. For this type of problem, you just need to figure out what is the cosine of 330 degrees and what is the sine of 330 degrees. You're going to replace those, and then you're going to just use your distributive property. So it's a very easy problem. So for the cosine of 330 degrees, you have a 30-degree reference angle, and you're in quadrant 4. So we know cosine is positive in quadrant 4. So you can just say this equals the cosine of 30 degrees. And so that's going to be square root of 3 over 2. Then for the sine of 330 degrees, again, you have a 30-degree reference angle. You're in quadrant 4, so sine is negative, right? So this is the negative of the sine of 30 degrees, which is negative 1/2. So let me put equals here. You can write this down if you want. This is something I think most of you have memorized, so I'm just going to erase it. And we're just going to replace this guy and this guy. So this would be 4 times the quantity. For the cosine of 330 degrees, again, that's square root of 3 over 2. And then plus I times, for the sine of 330 degrees, again, that's negative 1/2. Let's close that down. And actually for this one, let's just rearrange it, put the negative there, get rid of that. And I'm just going to slide this down here and put the I like that, just for formatting. So let's come down here a little bit, get a little room going. You're just going to distribute this 4 to each guy here, and you'll be done. So basically you have 4 times the square root of 3 over 2, then minus 4 times 1/2, then times your imaginary unit I. So let's finish this up. So 4 divided by 2 would give me a 2, and then 4 divided by 2 would give me a 2. So 2 times square root of 3 is what I'd have there. And then minus, basically 2 times the imaginary unit I. So 2 times square root of 3 minus 2I. Let me grab this, and let's paste this right here. So looking through my choices, this is what I want. So 2 times square root of 3, then minus 2I. All right, let's take a look at question 2 now. So we want to write each in rectangular form, or again, you can call that standard form. So we have 4 times, you're going to have the cosine of 0, and this is in terms of radians. You could also write 0 degrees if you want. Then plus I times the sine of 0. All right, so hopefully you remember from the unit circle that the cosine of 0 is going to be 1, and the sine of 0 is going to be 0. So basically what's going to happen here, let me actually get rid of this, it's just going to be in the way. You're going to have 4 times the quantity, cosine of 0 is 1, plus for sine of 0, that's 0. So you could write 0i if you wanted to. 0 times anything is going to be 0, right? So at the end of the day, this is just going to be 4, right? So you have 4 times 1 plus 4 times 0i, and this again is just going to be 0, so you just get 4. Now, if you wanted to write this in the a plus bi form, then of course you could say 4 plus 0i like that. But if we go back up, the way the question is written, you just want to put 4, right? So if you put, let's say as a free response, 4 plus 0i, that would be fine as well. All right, let's take a look at question 3 now. So we want to write each in polar form. So we are given 3 times square root of 2 over 2, then minus 3 times square root of 6 over 2, and then times I. So the first thing I'm going to do is figure out the value for R, right? Because these guys are going to go into R times your quantity. You have the cosine of theta, and then plus I times the sine of theta. So figuring out what R is, again, it's just the absolute value of the complex number. So you're just going to say that R is equal to the square root of, you take the real part, which is 3 times square root of 2 over 2 squared, and then plus the imaginary part, which is negative 3 times square root of 6 over 2, and that's going to be squared. Okay, so for this one, it's going to be a little bit tricky. So 3 squared is 9. Square root of 2 squared is 2. So that right there would be 9 times 2, and then down there, 2 squared is 4. So let me write this like this. We're going to have 9 times 2 over 4. And of course, you can cancel a common factor of 2 between numerator and denominator. So this would just be 9 halves. So let me write 9 halves here. Okay, for this one, the negative goes away. 3 squared is 9. Square root of 6 squared is 6. Let me actually erase this and kind of do this as I go. So this is going to be 9 times 6. And then down here, 2 squared would give me 4. Okay, so I'm going to cancel a common factor of 2 between numerator and denominator. So this would be a 2, and this would be a 3 up here. So now we would have 9 times 3, which is 27 over 2. So let me write 27 over 2. So we have a common denominator. So we can take 9 and add that to 27. That gives me 36. So this right here would be 36 over 2, which we know is 18. And then for 18, I'm just going to write it as 9 times 2 because 9 is a perfect square. So this becomes 3 times square root of 2. All right, so 3 times square root of 2. Now, because we're on a multiple choice test, you could actually stop right now if you wanted to and say, well, this is the answer we're going to get because no other r value is 3 times square root of 2. But let's just go a little bit further. Let me get rid of this. And let me actually just get this up here like this and say that this is equal to this. And I'll put some parentheses here. Now, getting your theta, which is known as your argument for this guy, is a little bit more tricky. Remember, you want to plot this as a position vector and then think about what's going on. So from the origin, you're going to go 3 times square root of 2 over 2 units to the right, and then you're going to go down by 3 times square root of 6 over 2. So again, looking at this from the origin, I'm going to the right by 3 times square root of 2 over 2, and then going down by 3 times square root of 6 over 2. So that would be my terminal point right there for the position vector. So what am I looking for theta? Well, it's going to be this angle right here, okay? So that angle, let's just say I put my theta right there. Well, again, to figure this out, you're going to use your inverse tangent function. So we would say that the tangent of theta is going to be equal to, you can go b over a or y over x, depending on how you notate things. But I just remember imaginary over real. So we're going to do negative 3 times square root of 6 over 2. And then if I'm dividing by this guy right here, I can just multiply by the reciprocal. So let's go 2 over 3 times square root of 2. So let's see what's going to cancel. This would cancel with this. This would cancel with this. Let's put a 1 there. And then if you think about, let me move my 1 down. If you think about the square root of 6 and the square root of 2, well, this could really be written as the square root of 2 times the square root of 3. So this would cancel with this. And let me just clean this up now. So you basically have negative 1 times square root of 3. So that's the negative of the square root of 3. And everything else down there has canceled. So let me get rid of all this. A little bit busy there. And move this up here. Okay. So we are going to say that we want the inverse tangent of this negative of the square root of 3. And what's going to happen is that's going to give me this angle right here, rotating clockwise, and that's going to be negative 60 degrees. Okay, so let me put negative 60 degrees. So how do I figure out what theta is? Well, basically, if you want this guy right here, you can think about, okay, I'm going to take the whole thing, which is 360 degrees, and then I'm going to take this piece out, right? So if you're going this way, you could say I'm adding negative 60 degrees, or if you're going this way, you could say I'm subtracting 60 degrees. Either way, you're going to get the same thing, which is 300 degrees. So we're going to say that theta is equal to 360 degrees. And let's go plus this negative 60 degrees like this. And so this would give me a final answer for theta that's going to be 300 degrees. Again, you could have also plugged this in as a positive and just said, I want to go into quadrant 4 and find an angle with a reference angle of 60 degrees. And again, it's the same thing. You would just say, okay, well, I want 360 degrees minus 60 degrees. That's going to give me 300 degrees. So coming back up, I just want to say that this is the cosine of 300 degrees plus I times the sine of 300 degrees. And the shorthand, again, you can do 3 times square root of 2, and then CIS, some people will say cis there, and then 300 degrees. So this isn't an answer choice, but just another way to write this. You'll see this a lot. So coming over here, this is what we want. So 3 times square root of 2 times, you have this quantity, the cosine of 300 degrees, plus I times the sine of 300 degrees. All right, for question 4, again, we are asked to write each in polar form. So we are given the negative of the square root of 3, and then minus I. I'm going to put minus 1i for clarity there. So to get the r value, again, it's the square root of, you're going to take the real part and square that. So the negative of the square root of 3 squared, and then plus your imaginary part, which is negative 1, and you're going to square that. So this is going to be the square root of the negative of the square root of 3 squared is going to be 3. And then negative 1 squared is going to be 1, so plus 1. So this is the square root of 4, which is going to be 2. Okay, let me get rid of all this. And let's say this equals 2 times. So what you want to do to find your theta is plot this as a position vector. So we want to go square root of 3 units to the left and then 1 unit down. So from the origin, square root of 3 units left and 1 unit down. So let's say that this is our terminal point here. And so this is the angle theta that we're going to be looking for. All right, so how do we get this? Again, you can say that the tangent of theta is equal to imaginary over real. So this is negative 1 over negative square root of 3. Let me make that 3 a little bit better. So this gives me what? 1 over the square root of 3. You rationalize the denominator. So you say the square root of 3 over the square root of 3. That's what I'm multiplying by. And this equals the square root of 3 over 3. So if I do the inverse tangent with square root of 3 over 3, what am I going to get? Well, this is going to give me 30 degrees. Let me get rid of all this. And let's think about what this means. Because I plugged in something positive for my argument in the inverse tangent function, I'm getting this guy right here in quadrant 1. So that's going to be this angle right here, which is 30 degrees. So again, if you want the correct angle for theta, you have to add this part right here, which is a straight angle. So you have to go theta is equal to that 30 degrees plus a straight angle, which is 180 degrees, which gives us 210 degrees. Now, again, another way you could have done that, you can go into quadrant 3, and you could say what angle has a reference angle of 30 degrees. So this is my reference angle of 30 degrees here. So that would be your straight angle. So now you're thinking about it like this. So this is your straight angle, and then plus your 30 degrees right there. So that's 180 degrees plus 30 degrees. Again, just reordering things. Either way, you're getting 210 degrees. So let's come back up and say that this is the cosine of 210 degrees, and then plus I times the sine of 210 degrees. Now, we are given radian measure here, so we need to just convert this over. A lot of you know that this is going to be 7 pi over 6, but just in case you don't, it's not that big of a deal. Let's just convert it real quick. So 210 degrees times pi over 180 degrees. So let's cancel this and this. Let's cancel a common factor of 10. So let's just get rid of this at this point. And you have 21 and 18. So 21 divided by 3 is going to be 7. And then 18 divided by 3 is going to be 6. So we get our 7 pi over 6. Okay, so you could write this as 2 times the cosine of 7 pi over 6 plus I times the sine of 7 pi over 6. And again, you could say 2 CIS or CIS, and then put that angle, so 7 pi over 6. Okay, so looking through my choices, it's going to be this guy right here. So 2 times the cosine of 7 pi over 6 plus I times the sine of 7 pi over 6. All right, let's take a look at question 5. So here, again, we want to write each in polar form, and we're just given the number -3. So again, you can think about this as -3 plus 0i if you need to. The r value here is what? Because if we're on a coordinate plane, the distance is just going to be 3 units, right? So from the origin, I travel 3 units to the left to get to that point. So coming back up here, you could show this with the formula. So it's the square root of -3, that's your real part squared, plus 0, that's your imaginary part squared. So of course, this is going to be the square root of 9, which is just going to be 3. So the r value there is just going to be 3. Okay, let me actually get rid of this and put this like this. So this is 3 times. You want the cosine of theta plus I times the sine of theta. Okay, let's go back. We know how to plot -3, 0. That's pretty easy. So this right here would be your terminal point. Now, if we think about the angle, again, it's going to be from right here. So it's going to be a straight angle, or an angle that is 180 degrees. So I think that's pretty obvious. So let's go back up and just write in 180 degrees here and 180 degrees here. And then everything's given in radians. So we know 180 degrees is exactly pi radians. So we can just say this is 3 times the quantity. You have the cosine of pi plus I times the sine of pi. And of course, you can say 3 CIS and then pi. So looking through my choices, looks like I want this guy right here. So 3 times the quantity cosine of pi plus I times the sine of pi. All right, let's take a look at the quiz. For the first question, we're asked to simplify, write in polar form. So we are given 2 times the quantity cosine of pi over 4 plus I times the sine of pi over 4. This is multiplied by 2 times the quantity cosine of pi over 6 plus I times the sine of pi over 6. Okay, for this, we're just going to use what we call the product theorem. So you're going to multiply the two absolute values together. So 2 times 2 is going to be 4. And then inside of the parentheses, we're going to go cosine of, you're going to add your arguments. So pi over 4 plus pi over 6. So pi over 4 plus pi over 6. So to do this, I'm going to get a common denominator going. So for this one, I would just multiply this by 2 over 2. And this guy, I would do 3 over 3. So this would end up giving me 3 pi over 12 plus 2 pi over 12. So let's say that this is 3 pi over 12 plus 2 pi over 12, which would be 5 pi over 12. So this right here is 5 pi over 12, then plus I times the sine of 5 pi over 12. So that's basically it. That's our answer. So let's grab this real quick and let's paste that in there and let's look for our answer. Looks like it's this first one right here. So we want 4 times the quantity cosine of 5 pi over 12 plus I times the sine of 5 pi over 12. All right, let's take a look at question 2. So we want to simplify and then write in polar form. So let's say that we have 6 times the quantity. You have the cosine of 3 pi over 4 plus I times the sine of 3 pi over 4. And then times, let's go 5 times the quantity, cosine of 7 pi over 6. And then plus I times the sine of 7 pi over 6. Okay, let's grab this real quick. Paste that in there. Again, all you have to do for this is just multiply the absolute values together. So 6 times 5 is going to be 30. And this is times the quantity cosine of, you're going to add the arguments. So you're going to have 3 pi over 4. Let me make that a little bit better there. And then plus, you're going to have 7 pi over 6. Now to get a common denominator, again, if you think about 4 and 6, the LCD is going to be 12, right? So I need to multiply this right here by 3 over 3, and this right here by 2 over 2. So this would be 14 pi over 12. So again, 14 pi over 12, and this is being added to, this would be 9 pi over 12. So 9 pi over 12. So let's do 9 plus 14. That's going to give me 23. So this would be 23 pi over 12. Then plus, you're going to have your imaginary unit I times the sine of the same thing, right? You're adding your arguments together. So we know that's going to produce 23 pi over 12. Close that down. And let's grab this real quick. So let me paste that in there. I know it's hard to read. But basically, we're looking for this one right here, where we have 30 times the quantity, cosine of 23 pi over 12, plus I times the sine of 23 pi over 12. All right, for question 3, we're asked to simplify and then write in rectangular form. So we have 2 times square root of 3. And let me just use the shorthand notation here. So remember, if you have cosine of 150 degrees plus I times the sine of 150 degrees, you can write CIS and then 150 degrees. So again, CIS, that's where that's coming from. So then times, I'm going to go with the shorthand here. So 4 times CIS and then 90 degrees. Let me grab that real quick. And let's paste this in here. And maybe I can fit this because it's shorthand over here. Okay, let's put equals. So working with the shorthand is actually a lot easier because you only have to do things once in terms of writing it. So maybe it's not easier, but just less tedious. So you're going to multiply the absolute values together. So 2 times 4 would be 8, and then times the square root of 3. And then you're just going to write CIS, and then you're going to add 150 degrees to 90 degrees, and that's going to give you 240 degrees. So very easy, very simple. Again, if you want to convert this over, you could just say this is 8 times square root of 3, and then times the quantity, the cosine of 240 degrees, and then plus I times the sine of 240 degrees. So it's just a little shorthand. We were told that we wanted to write this in rectangular form. So to do that, we need to think about what is the cosine of 240 degrees, and then what is the sine of 240 degrees? Well, we know that we're in quadrant 3 with 240 degrees. In each case, cosine is negative and sine is negative. So we'll think about the reference angle, which is 60 degrees. The cosine of 60 degrees is a half, so this would be negative 1/2. And the sine of 60 degrees is square root of 3 over 2, so this would be negative square root of 3 over 2. So you're just going to plug in. So let's go ahead and say that this is 8 times square root of 3 times the quantity. For the cosine of 240 degrees, that's negative 1/2. And then for the sine of 240 degrees, it's negative square root of 3 over 2. Let me get rid of this. And then don't forget your imaginary unit I. Let's just put that out there for right now. So you're going to distribute this guy in to each guy here. And let's go ahead and say that this is 8 times square root of 3 times negative 1/2. And then minus 8 times square root of 3 times square root of 3 over 2 times I. So let's say this is equal to, for this guy right here, the 8 would cancel with the 2 and give me a 4. So this is negative 4 times square root of 3. And then for this guy, the 8 would cancel with the 2 and give me a 4. And then square root of 3 times square root of 3 is 3. So this is negative 4 times 3, which is negative 12. So minus 12, and then times I. So this is the answer we're looking for. It's in the rectangular form, or the a plus bi. That's also called standard form. Let's paste this in. So I want this guy right here. So negative 4 times the square root of 3 minus 12i. All right, let's take a look at question 4. So here we're asked to simplify and then write in polar form. So we have 4, and let me just write this in shorthand. So I'm going to put CIS and then 240 degrees. This is over. You have 5 and then CIS 270 degrees. Let me grab this real quick and let me paste this in. So this is equal to, again, divide the absolute values. So this is 4/5. And then times, I'm going to go CIS. I'm going to subtract this guy minus this guy. So when you subtract your arguments, it's numerator minus denominator. So 240 degrees minus 270 degrees. So that's going to give me negative 30 degrees. Now, you could leave it like this if you wanted to, just depending on your teacher. But most people would prefer to write this in terms of its coterminal angle. So just add 360 degrees, and you're going to get 330 degrees there. Let me make that 0 a little bit better. And of course, you could write this as 4/5 times the quantity cosine of 330 degrees, and then plus I times the sine of 330 degrees. Let me make the 0 a little bit better there. Okay, let's grab this, and let's bring this in here. I know it's hard to read, but we're looking for this guy right here. So 4/5 times the quantity cosine of 330 degrees, plus I times the sine of 330 degrees. All right, let's take a look at question 5. So here we want to simplify, write in rectangular form. So let's say that we have the square root of 21, and then I'm going to go CIS 150 degrees over. We're going to have the square root of 17. Let's go CIS and then 90 degrees. Okay, let's grab this real quick and let's paste this in here. So all I'm going to do is divide the absolute values. So this is the square root of 21 over the square root of 17. Now, typically you want to rationalize the denominator. So times the square root of 17 over the square root of 17. So this right here, 21 times 17, that's going to be 357. So let's say this is the square root of 357 over 17. Then we're going to have our CIS, and then you're just going to subtract the arguments. So you go numerator minus denominator. So 150 degrees minus 90 degrees, that's going to be 60 degrees. Okay, so let's go ahead and write this as the square root of 357 over 17 times the quantity. You have the cosine of 60 degrees, then plus I times the sine of 60 degrees. Let me close that down, and let me put this like this. We want to write this in rectangular form. So you need to figure out what is the cosine of 60 degrees and what is the sine of 60 degrees, and then replace those, then use your distributive property. So let me put this as the square root of 357 over 17 times the quantity. We know the cosine of 60 degrees is a half. And then plus, we know the sine of 60 degrees is square root of 3 over 2, and then times I. So now all I'm going to do is just distribute this to each guy here. Let's come down, and we'll say that this is going to be the square root of 357 over 17 times 2 is 34. Maybe I can make the square root symbol a little bit better there. So let's do it like that. And then we're going to have plus. Here you have the square root of 357 times the square root of 3. So let's actually write that as the square root of 119 times the square root of 3 times the square root of 3. So you see what I'm doing here. So square root of 3 times square root of 3 is 3. So let's go ahead and say that this is 3 times the square root of 119. Let's make that 3 a little bit better there. And this is over 17 times 2, which is going to be 34. And then you could put the I here, or again, a lot of people would put the I like this. So either way, this is your A plus BI format. So let's go ahead and grab this for the answer. And so I'm looking for this guy right here. So we want the square root of 357 over 34 plus, here it's written a little bit differently, but you could have put 3i times the square root of 119 over 34. But the way it's written here is 3 times square root of 119 over 34, and then times the imaginary unit I. So you can just move this out here if you want, or you can just keep it here. Again, it's a matter of personal preference. All right, let's take a look at the quiz. For the first question, we're asked to simplify and then write in rectangular form. So here we have this complex number here. It's 3 times the quantity cosine of 5 pi over 6 plus I times the sine of 5 pi over 6. And this number here is raised to the 4th power. So we can use our little formula here. First, we would take 3 and raise that to the 4th power. We know that's 81, but let's replace that in a moment. Then we're going to have inside the parentheses the cosine of. You're going to take that exponent of 4 and you're going to multiply it by the argument. So 5 pi over 6. Let's simplify that in a moment. Let me drag this over here a little bit. So plus I times the sine of 4 times this 5 pi over 6. So what's this going to be equal to? 3 to the 4th power, we know that's 81. And then times this quantity, we'll have the cosine of the 4 and the 6 each have a common factor of 2. So if I divide 4 by 2, I get 2. 6 divided by 2 is 3. So this would be 10 pi over 3 in each case. And let me put plus I times the sine of 10 pi over 3. Okay, this is getting pretty busy. So let me actually get rid of this. And maybe I'll fix this a little bit. Okay, so what is the cosine of 10 pi over 3? And what is the sine of 10 pi over 3? Well, first I would recommend putting this in terms of its coterminal angle, because this guy right here is greater than 2 pi. So I would say 10 pi over 3 minus, let's just subtract away 2 pi. So let's go 6 pi over 3. And I wrote it like this so I could have a common denominator. So this would give me 4 pi over 3. So that's the coterminal angle. Let me get rid of this, and let me get rid of this, and let me get rid of this. So this is 4 pi over 3, and this is 4 pi over 3. So this guy right here, if you wanted to convert it to degrees, it would be 240 degrees. So you would have a 60-degree reference angle, and you'd be in quadrant 3. Okay, but I'm going to work with radians. I think a lot of you can do that at this point. So the cosine of 4 pi over 3, because we're in quadrant 3, this is the negative of the cosine of pi over 3. And for the cosine of pi over 3, it's a half. So this would be negative 1/2. And then for the sine of 4 pi over 3, well, I think we all know that this is going to be negative square root of 3 over 2. But maybe I can write this out in case somebody's lost. So it's the negative of, because again, we're in quadrant 3 and sine is negative, the sine of pi over 3, the reference angle. So this is negative square root of 3 over 2. So because we're going to run out of room, let me just replace this here. I'll just say this is negative 1/2. And let me make that 2 a little bit better. And let me replace this with negative. And then this would be square root of 3 over 2. So square root of 3 over 2. Let me put the I over here, get rid of that, and close this down. And let me get rid of this. And now we can just distribute. So the 81 is going to be multiplied by negative 1/2. So that's negative 81 over 2. And then the 81 is going to get multiplied by the negative square root of 3 over 2 times I. So let's put minus. I'll just put 81. Let's just put I like that, and then times square root of 3 over 2. And actually, it looks like I didn't put it like that in the answer, so let's put it like this so nobody is lost. So looking through the answers, I'm going to want this one right here. So it's going to be negative 81 over 2, then minus, you have 81 times square root of 3 over 2, and then times the imaginary unit I. All right, let's take a look at question 2. So we want to simplify and then write in rectangular form. So we have the quantity negative 5 and then minus 5i, and this is going to be squared. Okay, let's grab this real quick and let me paste this in. Now it's actually going to be quicker if you use your special products formula here versus converting this into polar form and then using your rule there. But let's just go ahead and do it both ways. So first, let's do it using our special products formula. So we know that the first guy here, which is negative 5, that would be squared. So this is negative 5 squared. And then minus 2 times the first guy, which is negative 5, times the last guy. Now you're not taking the sign with you here. Okay, you're taking it here, but not here. So this is going to be 5i, and then plus, just take that last guy, which is going to be 5i, and that's going to be squared. So to simplify, negative 5 squared is 25. And then negative 2 times negative 5 is 10. 10 times 5 is 50. So this is plus 50i. All right, then we have plus 5i being squared. So 5 squared is 25. So let me put plus 25. And then I squared, we know that's going to be negative 1. So let me actually convert this over to a minus here. And so 25 minus 25 is 0. So this is just equal to 50i. So that's going to be our solution. Now, the other way you can do this again, it's going to take longer in this particular case, you would convert this over into polar form first. So I would say that the r value is the square root of, you have -5 being squared plus -5 being squared. So this is 25 plus 25, which is going to be 50. So you have the square root of 50. So you can break that down and say this is 25 times 2, and the square root of 25 is 5. So this is going to be 5 times square root of 2. So let me write that this is equal to, we have 5 times square root of 2. And actually what I'm going to do here is put some brackets like this, because we're going to end up squaring this. So this is times the cosine of, I'll put blank, plus I times the sine of, and let me scooch this down a little bit, put my blank in there, close this down, and then do this like this. So what is theta? Remember, tangent of theta is equal to your imaginary part, which is -5, over your real part, which is -5, so that's 1. So I know that I'm in quadrant 3. From the origin, I'm going to the left, and then I'm going down. So that tells me that this guy right here, if I did the inverse tangent function with 1 as the argument, let me show that. So inverse tangent with 1 as the argument, we know that's 45 degrees, but again, I'm in quadrant 3, so I want to go 180 degrees plus 45 degrees to get myself to 225 degrees. Okay, let's put that in there like that. And let's say this is 225 degrees and then 225 degrees. Okay, let's get rid of this. So now we can use our little formula. So we're going to say that this is equal to, this guy right here is going to be squared. So 5 squared is 25. And then the square root of 2 squared is 2. And 25 times 2 is 50. So this is 50 times the quantity. You're going to have the cosine of, you'd multiply 225 degrees by 2, which is 450 degrees. And then plus I times the sine of 450 degrees. Let's close that down. Now what I would do to make this easier is just find the coterminal angle. So 450 degrees minus 360 degrees, that's going to be 90 degrees. So let's say this is 50 times the quantity of the cosine of 90 degrees plus I times the sine of 90 degrees. So we know that the cosine of 90 degrees is 0 and the sine of 90 degrees is 1. So this would become 50 times, let's just write this out. So this is 0 plus 1i, like this. So we'll end up with just 50 times 1i, or just 50i. So a lot longer to go this way and do it, but it does give us some practice. So let's just select our answer and say it's 50i. All right, let's take a look at question 3. So we want to find all nth roots in polar form. So here we have the negative of the square root of 3, and then minus, instead of just putting I, let's put minus 1i. So first I'm going to write this in my polar form so that I can use my formula. I would note here that the n is 5, so we want to find the 5/5 roots. So let's go through here and first find the polar form. So r is equal to what? It's the square root of, so the negative of the square root of 3 squared, then plus the imaginary part, so that's -1, that's going to be squared. So this right here, the negative would go away. The square root of 3 squared is 3. Let's put this as 3. And then -1 squared is 1, and 3 plus 1 is 4. So this would be the square root of 4, which is going to be 2. Okay, let me get rid of this, and let me slide this over here and say this is equal to 2 times the cosine of blank plus I times the sine of blank. For the theta here, the tangent of theta is equal to, you have -1, which is the imaginary part, over negative square root of 3, which is the real part. So the negatives would cancel. So it's 1 over square root of 3. So times square root of 3 over square root of 3, this would give me the square root of 3 over 3. Get rid of this, and let me slide this down. Now, we're going to be in quadrant 3, right? From the origin, we're going to the left, and we're going down. And in quadrant 3, we know that tangent is positive. So let's go ahead and say that the inverse tangent of this guy right here, so square root of 3 over 3, is equal to 30 degrees. But this is going to be our reference angle in quadrant 3. So you want 180 degrees plus 30 degrees. That's going to be 210 degrees. Let me put 210 degrees here. Okay, let me get rid of this. And actually, I believe our answers are given to us in radians. So let me convert this over. So 210 degrees, let's multiply this by pi over 180 degrees. So I'm immediately going to cancel the degree units, and then I'm going to cancel a common factor of 10. 21 is 7 times 3. and then 18, let's just do 6 times 3. So we cancel a common factor of 3, so this is 7 pi over 6. We get rid of this and get rid of this, and let's put 7 pi over 6, and then 7 pi over 6. Okay, so now let's go ahead and find the 5 fifth roots. So we have roots here. Let me come down here like this. So first off, in each case, you would want the fifth root of 2, okay? And I'm going to have to write this as CIS as the abbreviation because there's no way I'm going to be able to fit this, okay? So let me put this like this, and let me maybe put this one over here like this. And then we'll put this one like this. Let me come down a little bit, and I'll put the last one maybe like this. Or we'll just say this is the third one because we haven't really set anything up yet. So let's go ahead and put this like this. Okay, so what is the first guy here? Keep in mind, I've cut off my theta. Let me write that over here. So theta is equal to 7 pi over 6. In the first case, all you need to do is divide this guy right here by whatever your n is. So the n is 5. So you just want, let me do this off to the side because it's going to be a mess. So we want 7 pi over 6 divided by 5 or times 1/5. So this becomes 7 pi over 30. Okay, so that actually wasn't that bad. So this is 7 pi over 30. So the first one is always the easiest one because in your formula, basically you would say that this alpha, which is this angle here, is going to be equal to, you first start off with theta divided by n. Okay, so theta here is 7 pi over 6 divided by n is 5. So that's why we did 7 pi over 6 divided by 5. We got 7 pi over 30. Then plus, you're going to have your 2 pi times k over your n. Now, k starts out at 0, so that's why this is just 7 pi over 30, because this part's going to go away, right? So you go k as 0, 1, 2, 3. It goes all the way up to n minus 1. In this case, n is 5, so we're going to go up to 4. So in each case, all you're really going to do is take whatever the previous guy was, and you're going to add, forget about the k, let's just get rid of that for a moment. You're going to add 2 pi over n, and n, again, is going to be 5. So each time we're adding 2 pi over 5 to what we found previously. So let's actually do that here. So we have 7 pi over 30. So then plus, we're going to add 2 pi over 5. So this right here would be what? I'd multiply this by 6 over 6. So this would be 12 pi over 30. So this would give me 19 pi over 30. Okay, so that's going to be the second one. And we could just keep going here. So let me put a comma. You're going to have 19 pi over 30. Now I'm going to add 2 pi over 5 again. So times 6 over 6. So this would be 12 pi over 30. And this is going to give me 31 pi over 30. So 31 pi over 30. So that's the third one. For the fourth one, it's 31 pi over 30, then plus, again, 2 pi over 5. So again, we could just multiply by 6 over 6. So this would be 12, and this would be 30. So 31 plus 12, that's going to be 43. So this is 43 pi over 30. So 43 pi over 30. And then for the last one, you're going to take 43 pi over 30. And we know that this is going to be plus 2 pi over 5, or again, if I multiply by 6 over 6, it's 12 pi over 30. Let me put that down there. 43 plus 12, that's going to be 55, so this is 55 pi over 30. So 55 pi over 30. And I know this is a lot of scratch work. Let's come back up, and let's paste this in here, just temporarily. So the second one is 19 pi over 30. Let me make that fraction bar better. The third one is 31 pi over 30. Maybe the 3 could be better there. Let me erase these as I go. The fourth one is going to be 43 pi over 30. And the fifth one is 55 pi over 30. Okay, let me get rid of this. And before we look for this 55 pi over 30 can be reduced. So this guy right here, if I divide this by 5, I get 11. And if I divide this by 5, I get 6. Everything else is simplified. And because this is so lengthy, I'm just going to go to the answer one. So it's going to be E that we want. That's our choice. So we have everything that we found on the previous page. So let's come down here and just select choice E. All right, let's take a look at question 4. So here we want to find all nth roots in polar form. So for this guy, let's write it in polar form. So the r value would be what? It's the square root of, basically this guy and this guy, they're different by only the sign. So let's just say this is 2 times this square root of 46 over 2 being squared. Again, if you want to write it as the square root of, you could take negative square root of 46 over 2 being squared plus the square root of 46 over 2 being squared. If you want to do it like that, that's fine. This is going to give you the same answer. So the square root of 46 being squared is going to be 46, and then 2 being squared is 4. And so you're basically going to multiply this by 2. And so this would cancel with this and give me a 2. And then 46 divided by 2 is 23. So this is the square root of 23. So let me put that this is the square root of 23. And then times, for this guy, actually, let me write this in the shorthand. I think that's a little easier. So CIS or the CIS. For theta, we know that the tangent of theta, again, is imaginary over real. So if I take the square root of 46 over 2 and divide it by the negative of the square root of 46 over 2, that's going to be negative 1. Right? So this is negative 1. Again, think about where you are. This is negative and this is positive. So from the origin, I'm going to the left and I'm going up. So I'm in quadrant 2 where tangent is negative. But if I was to say the inverse tangent of negative 1, I'm getting negative 45 degrees. So something in quadrant 4 where tangent is also negative and rotating clockwise. So I have to add 180 degrees to that to swing myself around into the correct quadrant that I want to be in. Right? So I would have to say that this is negative 45 degrees plus 180 degrees, which is 135 degrees. Again, if you don't like doing it that way, you could also just say that I want the inverse tangent of, let's say 1. Okay, you can make the argument positive. That would give me 45 degrees. So I'm going into quadrant 2 and saying, what angle has a reference angle of 45 degrees? Well, 180 degrees minus 45 degrees would give me that 135 degrees. Okay, so now we want to find the 4 fourth roots here. And so let's just use our formula. Let me put this right there. So let me say this is the roots. The first part is a little bit complicated. Remember, it's the nth root of whatever r is. Well, in this case, you want the 4th root of the square root of 23. And I think a lot of people see that and they start thinking about, well, how am I going to simplify that? So what I'm going to do is actually write this in exponential form just to make it easier to comprehend what's going to happen. You can always do that legally. So the square root of 23, I can write that as 23 to the 1/2 power. And then if I wanted to raise this to the 1/4 power, or again, take the 4th root, well, all I have to do is use my power to power rule. This is 23. That stays the same. Multiply exponents. 1/2 times 1/4 is 1/8. So you could write it like that, or you could say it's the 8th root of 23, whatever you want to do. So let's say this is the 8th root of 23. Now we're going to have 4 of these. Again, hard to fit this. So let's do CIS just to abbreviate. So this is the first one. The second one, let's write this one over here as the 3rd one. And let's write this as the 4th one. Okay, let's come down here. Now I'm going to cut off my angle because it's just not going to fit. It's 135 degrees. So again, when you think about this, for the first guy here, your formula for alpha, or this angle, it's again theta divided by n plus 360 degrees times k over your n. Okay, so in this particular case, theta is 135 degrees. So this is 135 degrees, and your n is going to be 4. So this is your starting point because, again, your n value is 4, and your k value starts at 0 and goes up to 1 less. So it's 0, 1, 2, and then 3. Well, when this is 0, this is going to go away, and I'm just left with this. 135 degrees divided by 4, that's going to be 33.75 degrees. Let me make that a little bit better. In each case, you're just adding 360 degrees divided by 4, or 90 degrees, to each angle that you found before. So 33.75 degrees plus 90 degrees, that's going to be 123.75 degrees. So much easier if you're not using radians because you don't have to deal with fractions. Add 90 degrees again, it's 213.75 degrees. Add 90 degrees again, and you're going to get 303.75 degrees. Let me put a comma here and here. So these are our 4 fourth roots, and looking through the answers, it's going to be choice E. This is the one you're going to want. So let's come down here and circle choice E. All right, let's take a look at question 5. Here we're asked to find all complex solutions in polar form. So we have x to the 4th power plus 1 equals 0. Again, you can always just say this is x to the fourth power is equal to -1, and you're trying to find something for x that when I plug in and I raise it to the fourth power, I get -1. Well, again, all you need to do is say, what are the 4 fourth roots for -1? If I find a fourth root for -1 and I plug it in for x and I raise it to the fourth power, I'm getting -1. Therefore, I've satisfied the equation. So let's go ahead and write -1 in polar form. So this would be -1 plus 0i. So the r value, again, if you have something like this, it's just going to be 1, right? The way you can think about this is the square root, r is the square root of -1 squared, which is 1, plus 0 squared, which is 0. So it's just the square root of 1, which is going to be 1. So this is 1 times the quantity cosine of, let me get rid of this. What is the argument here? Again, you don't need to do any complex analysis. You just think about the fact that if you're on the coordinate plane, well, -1 plus 0i, all I'm doing is I'm traveling 1 unit to the left. So that is my vector like that. So the direction angle is going to be 180 degrees. So this right here is going to be 180 degrees, or you can just do pi if you want to work with radians. I think maybe 180 degrees would be a little bit simpler. Then let's go plus. You have I times the sine of 180 degrees. Now remember, the sine of 180 degrees is 0, and the cosine of 180 degrees is -1. So if you distribute this, and you say this is -1 and this is 0, you're right back to this, okay? So now what we want to do is find the 4 fourth roots. So let's go ahead and say that x is equal to, x is equal to, and then x is equal to, and x is equal to. Let me put a comma and a comma. And in each case, for the 1, if you take the fourth root of 1, you get 1. So you can put it there or you can leave it off. I'm just going to leave it off. I think we know that we don't need that. You're just going to put CIS and then CIS and then CIS and then CIS. Let me come down here. You would take your alpha and say it's this angle, which is 180 degrees, divided by your n, which is 4. 180 degrees divided by 4, that's going to be 45 degrees. So this is 45 degrees to start. And then that 45 degrees is plus, again, 360 degrees times k over n. So 360 degrees divided by your 4 there, that's going to be 90 degrees. So this is 90 degrees times k. Now, k is going to start off being 0. That's why this guy's 45 degrees. But then you're going to go 1, and then 2, and then 3. So always 1 less than whatever n is. So let me get rid of this. We know we're just going to add 90 degrees to each previous solution. So 45 degrees plus 90 degrees, that's going to be 135 degrees. Then I add 90 degrees again. That's going to be 225 degrees. Then I add 90 degrees again, and I'm going to get 315 degrees. So this is what I'm looking for. So we want choice C. So let's come down here and select choice C. All right, let's take a look at the section quiz. For the first question, we're asked to simplify each. So let's write this out. We have -11 and then minus the quantity, -48, then minus I. Instead of writing minus I, let's put minus 1I. Then you have plus the quantity, -22 minus 14I. Okay, for these types of problems, you're going to add what you can. So in other words, if you have something like A plus BI, and then plus C plus DI, well, we know that we can add the real parts together. So A plus C. So A plus C. And then plus, let me actually group this so it's more clear. You have your B, which is the imaginary part here, and your D, which is the imaginary part here. So you could actually group those together and say B plus D, and then times the imaginary unit I. So in other words, it's like I'm doing BI plus DI, and I'm just factoring the I out. So that's all we're doing. So here, in order to accomplish this, let me get rid of this. You first have to get rid of the parentheses. And so with this guy right here, because you have a plus, you can just drop the parentheses. But over here, because you have a minus out in front, what's going to happen is you have to subtract each term away. So again, a trick for that, we put plus, put a -1 there, and then just distribute that to each term. So let's say this is -11, and then basically -1 times -48 would be plus 48. And then -1 times -1i would be plus 1i. And then here I can just drop the parentheses, so minus 22 and then minus 14i. Now, once you get good at this, you can just combine what you can. For clarity, and because we're in a tutorial, I'm just going to reorder things. So I'm going to write all the real parts next to each other. So -11 plus 48 and then minus 22. And then the other guys, let's go plus 1i, and then minus 14i. And again, you can pull the I out to make that more clear. So you could say this is 1 minus 14 in parentheses, and then put the I behind. Let me drag this up here. So now what I'm going to do is just key this into my calculator. Negative 11 plus 48 minus 22. That's going to give me 15. And then plus, here you have 1 minus 14, which is negative 13. And then times your imaginary unit I. Let's just go ahead and write minus 13i like this. So this is your A plus BI. So A is 15, B is negative 13, and then there's your imaginary unit I. So let's grab this real quick, and we'll just bring this down here and paste it in. And so this is what I want. So 15 minus 13i. All right, let's take a look at question 2. So we're asked to simplify each. So here we have 8 minus 5i, and then times, you're going to have negative 7 plus 6i, and then times, you have negative 1 plus 3i. Okay, let's grab this real quick and just paste this in right there. So basically with this, you're just going to pick 2 of them. I'm just going to pick the first 2. You could go in any order. You're going to multiply them together. You get that product, and you multiply that by the last guy. Okay, so I'm just going to go with the first 2, get the product, then multiply this by the third guy here. So I'm going to start with 8 times negative 7. That's negative 56. Then 8 times 6i. That's going to be plus 48i. Then negative 5i times negative 7. That's going to be plus 35i. And then we're going to have negative 5i times 6i. That's going to be minus 30i squared. So let's stop for a moment and simplify this. We know that I squared is negative 1. So basically, it's like I have negative 30 times negative 1. So it's going to give me positive 30. When you see this, just change the sign of what this is. So if it's a minus, it goes to a plus. If it's a plus, it goes to a minus. It's just changing the sign. So here we have negative 56 plus 30. So that's going to be negative 26. So this is negative 26. Now 48i plus 35i, that's going to be 83i. So let's write that in there. And now let's wrap this like this. And I'm going to bring this guy down. So the last guy, negative 1 plus 3i. Okay, so negative 26 times negative 1 is 26. Negative 26 times 3i, that's going to be negative 78i. And then 83i times negative 1 is going to be minus 83i. Then lastly, 83i times 3i, that's going to be plus 249i squared. Now again, the I squared is negative 1, and if you multiply by negative 1, you're just changing the sign. So you can just get rid of this and change this into a minus. Again, if it had been a minus, you change it into a plus. So you're just changing the sign. So 26 minus 249, that's going to give me negative 223. And then negative 78i minus 83i, that's going to give me negative 161i. All right, so this is going to be our answer here. Let's grab it real quick, and let's just paste this in here. So this is the one we want. So negative 223 minus 161i. All right, let's take a look at question 3. So we're asked to simplify each. We have negative 9 minus 6i over, we have 10 plus 4i. Okay, so if you want to simplify, and again, you have I in the denominator, and this has 2 terms here, well, basically what you're going to do is you're going to multiply the numerator and denominator by the complex conjugate of the denominator. So again, keep this guy and this guy the same, just change the sign. So in other words, it's 10 and it's 4i, because this is a plus, this will be a minus. So this is 10 minus 4i. So let's make our fraction bar there, and let me wrap everything for clarity. So we know that we're doing multiplication here. And essentially on the top part here, or for multiplying the numerators, we're just going to use FOIL. So negative 9 times 10, that's negative 90. And then negative 9 times negative 4i, that's plus 36i. And then negative 6i times 10, that's going to be minus 60i. And then negative 6i times negative 4i, that's going to be plus 24i squared. Again, for I squared, it's negative 1. So that's just like me changing the sign. So I'm going to get rid of this and make this a minus. So negative 90 minus 24, that's going to be negative 114. So let me write negative 114 up here. And actually, let me slide this down so everything fits. And that didn't come with that, so let me do that again. And let me also write this down here for clarity. So this is negative 114. And then 36i minus 60i, that's going to be negative 24i. So let me write minus 24i here. And let me get rid of all this. Now, down here, you don't have to use FOIL because you can use a formula. Again, if you have a plus b, then times this a minus b, this is a squared minus b squared. So we know this already. If you throw an I into the mix here and also here, then what's going to happen is this right here becomes b squared times I squared. And we know I squared is negative 1, so this becomes a plus here. Okay, so just take the first guy 10 and square that. That's 100. And then go plus. Take this guy 4 here and square that. That's going to be 16. So let's get rid of this. And 100 plus 16 is going to be 116. Okay. So we are not done. You'll notice that this guy's even, this guy's even, this guy's even. So that tells me that I can at least pull out a 2 and possibly even a 4. But if I look at this, I know that, again, for the rule for divisibility by 4, you look at the final 2 digits. And in this particular case, 14 is not divisible by 4. So it looks like I can just pull out a 2. So let's say this is 2 times negative 114 divided by 2 would be negative 57. And then negative 24 divided by 2 would be negative 12. And then let's put our I there. And this is over. 116 divided by 2, that's going to be 58. So let's put 2 times 58 like this. And I'll go ahead and cancel a common factor of 2 between numerator and denominator. So now let's write this as negative 57 minus 12i over the common denominator of 58. Now we know that legally we can split this up if we want to write this in standard form for a complex number, the a plus bi. You're going to say this is equal to negative 57 over 58. So that's the real part. And then you can go plus negative 12i over 58. So that's the imaginary part. Now, when you split it up like this, for this part right here, you can actually simplify a little bit more because this is an even number and so is this one. Let me actually write this as a minus here and get rid of the negative. So for 12, if I divide it by 2, I get 6. And 58 divided by 2, that's going to give me 29. And actually, let me get rid of this and move it out here. So this is your a plus bi. So let me grab this real quick and let's paste this in. And looking through, this is the one we want. So negative 57 over 58 minus 6 over 29 times the imaginary unit I. All right, let's take a look at question 4 now. So we're asked, what is the standard form of the complex number plotted, and it says point in yellow, on the given graph? So basically, when you think about the complex plane, the x-axis is now the real axis, and the y-axis is now the imaginary axis. So let's just pretend we have a normal coordinate plane. What is this point right here? Well, we're going 5 units to the right and 3 units up, right? So this point right here is 5, 3. But writing this as a complex number, again, I moved 5 units to the right on the real axis. So let's put 5. That's for my a, or my real part. And then I moved 3 units up on the imaginary axis. So let's put plus 3. That's going to be my b, or my imaginary part. And then we need to multiply this by the imaginary unit I. So in standard form, this would be 5 plus 3i. Let's copy that. And let's paste this in here. And looking through here, we want this one. So this is 5 plus 3i. All right, let's take a look at question 5. So here we want to find the absolute value of the given complex number. So we have the absolute value of negative 23 and then minus 39i. So this is a very simple formula. You just take the principal square root of. You're going to take your real part right here, which is negative 23, and you're going to square that. And then plus, you're going to take your imaginary part here, which is negative 39, and you're going to square that. So let's first square negative 23, and that's going to give us 529. So let's say this is 529. Let's square negative 39. So when I key that into my calculator, I get 1,521. Let's add these guys together, and I get 2,050. So this is 2,050. All right, so what I'm going to do here is think about the fact that it ends with a 0. So I know it's divisible by 10. And so that would give me 205 times 10. Now this ends with a 5, so I know it's divisible by 5. If I divide 205 by 5, I'm going to get 41. So you can go ahead and say that this is 41 times 50. just to make that a little bit easier. Let me put this up here. So this is 41 times 50. Now, 41 is a prime number. 50 can be broken down into 25 times 2. And so this guy right here, you can pull the square root of 25 out. That's going to be 5. And then times the square root of 41 times 2 is going to be 82. So that would be my answer for the absolute value of this complex number. Let's move this up here. So I want this one right here, which is 5 times the square root of 82. All right, let's take a look at question 6. So we want to write in rectangular form. We have 6 times the quantity, the cosine of 120 degrees, plus I times the sine of 120 degrees. So we know that a 120-degree angle is in quadrant 2, and it has a reference angle that's 60 degrees. In quadrant 2, sine is positive, and the sine of 60 degrees is square root of 3 over 2. So let me write square root of 3 over 2 here, times I like this. And let me put a plus here. Let me put a 6 here. Now the cosine of 120 degrees, we know that's negative because cosine is negative in quadrant 2. And then with a 60-degree reference angle, the cosine of 60 degrees is a half. So this is negative 1/2 here. So let me put equals, and you're just going to distribute that 6 to each guy. So this is 6 times negative 1/2 plus 6 times square root of 3 over 2 times I. So let's cancel this with this. 6 divided by 2 is 3. Let's cancel this with this. 6 divided by 2 again is 3. So this is going to give me, let me actually erase this step here and drag this up here like this. And I will say that this is negative 3 and then plus 3 times square root of 3 times the imaginary unit I. Again, a lot of people and a lot of textbooks will actually write this a little bit differently. You may see them put this as 3i times square root of 3 like this. So I'll just put another version here. So negative 3 plus 3 times square root of 3 times I. The reason this is done, and I've talked about this a lot, you don't want to get confused there and think that the imaginary unit I is underneath the square root symbol. So that's why we typically put it like this. All right, so looking through the choices, it looks like I'm going to want this one right here. So you want negative 3 plus 3i times square root of 3. All right, let's take a look at question 7. So now we want to write in rectangular form. So we have 3 times the quantity. You have the cosine of 180 degrees, then plus I times the sine of 180 degrees. Okay, we know that the cosine of 180 degrees is negative 1, and the sine of 180 degrees is 0. So you can just say that this is 3 times basically just negative 1, right? Because this is going to be 0, so it's gone, okay? So this is just going to end up being negative 3. Now, if you look through your choices, this is the one you want. Another way you could have done this, and I know a lot of people want to write this as negative 3 plus 0i, so you can do that. You could have said that this is 3 times, let me just do this. So this is negative 1 plus, you're going to put, again, this is 0, so 0i. So let's say this is 3 times negative 1 or negative 3, and then plus 3 times 0 would be 0. So you could put the 0i here. Again, 0 times anything is 0. So really this is just equal to negative 3. But another way to write this is negative 3 plus 0i. So on a test where you have free response, you could use this answer or this answer, but we're not presented with this, so we're going to go with just negative 3. All right, let's take a look at question 8. So we want to write in polar form. So here we have the negative of 5 times square root of 3 over 2, and then minus 5 over 2 times the imaginary unit I. So the first thing is, if you want to write something in polar form, it's going to look like this. So r times the quantity cosine of theta plus I times the sine of theta. So you need r and you need theta. Okay, so in other words, you need a direction and you need a magnitude, because you're thinking about this as, what if I wanted to sketch this as a position vector? So let me get rid of this, and let's first think about, well, what is the r value? Again, that's just the absolute value of the complex number. So you're going to take the square root of this guy squared plus this guy squared. So negative 5 times square root of 3 over 2, we're going to square that. And then plus negative 5 halves, we're going to square that. So this would be equal to the square root of, for this guy, it's a little bit tricky because there's a lot going on. The negative is going to go away. 5 squared is 25. The square root of 3 squared is 3. And then 2 squared is 4. Let's go plus. Over here, the negative goes away. 5 squared is 25. And then 2 squared is 4. So this is going to end up giving me 25 times 3 is 75. So you have 75 plus 25, which is 100. over the common denominator of 4. And 100 over 4 is 25. And the square root of 25 is going to be 5. Okay, let me get rid of all this. The r value is going to be 5. So let's just put this as equals and then put 5 here. Now, again, we see that we only have one guy here with an r value of 5. So provided you did this correctly, we know that this is the answer. But let's just continue. So we're going to say that this is times the cosine of blank plus I times the sine of blank. Now, how do we get this theta in each case? Again, you can use your inverse tangent function, and I would plot this to figure out where I am. So I'm going to go 5 times square root of 3 over 2 units to the left, and then I'm going to go down by 5 over 2. So looking at this guy, again, starting at the origin, I'm going to go to the left by 5 times square root of 3 over 2, and then down by 5 over 2. So this right here is the terminal point for this position vector here, which represents our complex number. So the angle theta is going to look like this, right? So it's going to be in quadrant 3. So I'm going to use my inverse tangent function. So inverse tangent of, you always want to go imaginary over real. Okay, so imaginary over real. This is your imaginary, so negative 5 halves, times your reciprocal of the real, right? Dividing fractions, you just multiply by the reciprocal. So let's say this is negative 2 over 5 times square root of 3. Okay, so what is this going to give me? The negatives are going to cancel, 5s are going to cancel, 2s are going to cancel. Let's put a 1 up here. And actually, I'm just going to erase this to make it a little bit more clean. This is 1 over the square root of 3. So times the square root of 3 over the square root of 3. So this would be the square root of 3 over 3. So the square root of 3 over 3. Now we know that the inverse tangent of square root of 3 over 3 is going to give us 30 degrees, or you can go pi over 6 if you want to work with radians. But this is not a 30-degree angle. What's happening is, so this guy right here, which is 30 degrees, right? So if you plug in a positive guy there for your inverse tangent function, you're getting something in quadrant 1. So what do we need to do to correct and get our angle in quadrant 3? Well, all we're going to do is add a straight angle here. So this right here would be plus 180 degrees. So we're going to say that theta is equal to my 30 degrees here, plus my straight angle. So that's 180 degrees. So this would give me 210 degrees. Now, again, another way you could do this, just think about an angle in quadrant 3 with a 30-degree reference angle. So in other words, you would want this guy right here for the reference angle. So in that particular case, you would start off with the straight angle, so 180 degrees, and then add 30 degrees, you're still getting 210 degrees. So let's come back up and say that this is 210 degrees, and this is 210 degrees. But again, we're given our answers in radians. So you just need to convert over. I think pretty much everyone knows that it's going to be 7 pi over 6. So you want this one right here. But let's convert it over in case you're a little bit lost. So 210 degrees, you'd multiply by pi over 180 degrees. And so the degrees are going to cancel. And then basically you can get rid of a common factor of 10, and then you can remove a common factor of 3. So 21 divided by 3 is 7, and 18 divided by 3 is 6. So this is 7 pi over 6. So this becomes 5 times the quantity cosine of 7 pi over 6 plus I times the sine of 7 pi over 6, or you can write 5 CIS 7 pi over 6. So 5 says 7 pi over 6. That's another way to do it. So this is our answer right here. All right, let's take a look at question 9. So we're asked to write in polar form. And here we have the square root of 3 plus I. Let's just go ahead and write 1I. And so first you want to find the R value. So R is equal to the square root of, again, the real part squared. So the square root of 3 squared plus the imaginary part, which is 1 squared. So square root of 3 squared is 3. 1 squared is 1. 3 plus 1 is 4. So this would be the square root of 4, which is 2. So that's the R value. So let me just write that right here. And then times, again, the quantity, you have the cosine of theta plus I times the sine of theta. All right, so let's just go ahead and sketch this guy. It's going to be in quadrant 1. So from the origin, you're going square root of 3 units to the right and then 1 unit up. So you're going square root of 3 units to the right, 1 unit up. So let's say we're going to be right there. So this one's really easy. Because we're in quadrant 1, you can just key this in to the inverse tangent function. So theta is equal to, you would have the inverse tangent of imaginary, which is 1, over real, which is square root of 3. We know if we rationalize the denominator here, so times square root of 3 over square root of 3, you're going to get square root of 3 over 3. So this is square root of 3 over 3. And we know the inverse tangent of square root of 3 over 3 is 30 degrees. So this is going to be 30 degrees. Let me make that degree symbol a little bit better. So that's this angle right here. And again, you don't need to make any adjustment because you're in quadrant 1. So let's come back and just say that this is 30 degrees and this is 30 degrees. And in terms of radians, I think we all know this is pi over 6, but again, you can convert it over. So 30 degrees times pi over 180 degrees. Forget about the degree unit because that's going to cancel. And then 180 divided by 30 is going to be 6. So this becomes pi over 6. So let's say that this is equal to 2 times, you have the cosine of pi over 6 plus I times the sine of pi over 6. Again, you could write 2 cis pi over 6. So looking through my choices, I want this one. So 2 times the quantity cosine of pi over 6 plus I times the sine of pi over 6. All right, let's take a look at question 10 now. So we're asked to simplify and then write in polar form. So I've given you a little hint here. It says convert each to polar form first, then use the product theorem. So we start off with 5 times square root of 2 over 2 plus 5 times square root of 2 over 2 times I. So let me grab this real quick. I'm going to convert it over. Let me paste this in here. So this will be equal to, you're going to find the R value first. So this is the square root of, you take your real part, so 5 times square root of 2 over 2 squared, then plus you take your imaginary part, which is the same, it's 5 times square root of 2 over 2 squared. Okay, so in each case here, 5 squared is 25, the square root of 2 squared is 2, and then 2 squared is 4. So basically, you can cancel a common factor of 2 between numerator and denominator. So you'd have 25 over 2 in each case. So 25 over 2 plus 25 over 2 is going to be 50 over 2. And 50 over 2 is 25, and the square root of 25 is 5. So this right here would be 5 times the cosine of, again, theta plus I times the sine of theta. For your theta, or what we call the argument, what we would do is say that the tangent of theta is equal to, you would go imaginary over real. So in this case, the imaginary and the real are the same. If I divide the same non-zero number by itself, I get 1. So we know if we use the inverse tangent function here, we're going to get 45 degrees. And so because this guy is positive and this guy is positive, in other words, from the origin, I'm going to the right and then I'm going up, I know I'm in quadrant 1, so this guy is exactly the angle that I'm looking for. So this would just be 45 degrees, or you could use pi over 4 if you want to use radians. So let's get rid of this and put times. We'll go back. So now we want negative 2 times square root of 2 plus, let's put 2 times square root of 2, and I'll put the I out here. All right, let's paste this in. So we'll say this is equal to the R value here. Again, this is the square root of. You're going to take this real part. So negative 2 times square root of 2, that's squared. And then plus, you're going to take the imaginary part. So 2 times square root of 2, and that's squared. All right, so for this one, if I square negative 2, I get 4. And then this is times the square root of 2 squared is 2. So then 4 times 2 would give me 8. So let me erase this. This would be 8 here, and this would also be 8. So 8 plus 8 would be 16. And of course, the principal square root of 16 is 4. So this becomes 4 times the cosine of theta plus I times the sine of theta. Now for this one, let me come down here a little bit and get some room. The tangent of theta is equal to imaginary over real. So I think we can see that's going to be negative 1. You have 2 times square root of 2 over negative 2 times square root of 2. So this would just be negative 1. So the tangent of theta is equal to negative 1. If you do the inverse tangent, so the inverse tangent, with negative 1 as the argument, you're going to get negative 45 degrees. Now let's think about this for a moment. The negative 45 degrees is going to be in quadrant 4, and that's rotating clockwise. If you think about where this guy is, it's negative in terms of the real part, and it's positive in terms of the imaginary part. So from the origin, I'm going to the left, and then I'm going up. So that means I'm going to be in quadrant 2. So all you would have to do is take that negative 45 degrees and add 180 degrees to correct, and then basically you would have 135 degrees, okay? So this is 135 degrees here and 135 degrees here. Now, if you don't like the way that I just mentioned, what you could also do is say, I'm going to go into quadrant 2, and I'm going to find an angle with a reference angle of 45 degrees. So you could do that as well. So either way, you would get a theta that's 135 degrees. Okay, let me get rid of this. And let me slide this up here. And so if we multiply these guys together, you multiply the absolute values. 5 times 4 is going to be 20. And then times, you're going to have your cosine of, you're going to add the arguments. So 45 degrees plus 135 degrees, that's going to be 180 degrees. Then plus I times the sine of 180 degrees. So let me close that down. Let's grab this real quick, come back up, and paste that in there. Now, everything is given in terms of radians, and we know that 180 degrees is pi radians, so we can just make that substitution. Let's get rid of that and get rid of that. So I want 20 times the quantity. You have the cosine of pi plus I times the sine of pi. All right, let's take a look at question 11. So here we're asked to simplify and then write in polar form. So let's just go ahead and say this is 3 times square root of 3 minus 3 times I. Let me move this over here real quick. And then we have negative 3 minus 3i times square root of 3. Okay, let's grab this real quick and let's paste this in. So the first thing we need to do is convert each of these over into polar form. So for this one right here, for the r value, it's the square root of, you have this 3 times square root of 3 being squared, plus this negative 3 being squared. So this right here, 3 squared is 9, times the square root of 3 squared is 3. So this would be 27. And then plus, over here, negative 3 squared is going to be 9. So 27 plus 9 is going to be 36. So this would be the square root of 36, which is going to be 6. So this right here is 6 times the cosine of, actually, let me write this in the shorthand. So let me go CIS. I just need to figure out what is the theta here. So we would go the tangent of theta is equal to, again, you can go y over x, you can go b over a. It's imaginary over real. So imaginary here is negative 3. And then the real here is 3 times square root of 3. So let's cancel this with this. And so this is negative 1 over square root of 3. I would rationalize the denominator here and say this is times the square root of 3 over the square root of 3. So this becomes the negative of the square root of 3 over 3. All right, let me get rid of this and move this down here like this. All right, so forget about the negative. I'm just going to go inverse tangent of square root of 3 over 3. And this is going to give me 30 degrees. So if I think about it, from the origin, I'm going to the right, and then I'm going down, right? So I'm going to be in quadrant 4. So I'm looking for an angle in quadrant 4 with a reference angle of 30 degrees. So that's going to be 360 degrees minus 30 degrees, which is 330 degrees. So 330 degrees. Now, you could have also plugged this in as a negative here, and this would give you a negative here. So this is rotating clockwise in quadrant 4. So for this one, you would just add 360 degrees to find the coterminal angle, and that would also give you 330 degrees. So whatever you want to do there. Okay, so this would be multiplied by, over here, now I need to find my r value. So r is equal to the square root of, so you have negative 3 being squared here, and then plus you have negative 3 times square root of 3, and this is squared here. Okay, so negative 3 squared is going to be 9. And then this negative 3 here being squared would be 9. And the square root of 3 squared is 3. So this would be 9 times 3. So this is 27 plus 9, which again is 36. So you would have the square root of 36, which is 6. So the r value here is 6 as well. And let's go CIS. And then for the theta, or the argument, again, you're going to say that the tangent of theta is equal to, you're going to go imaginary over real. So negative 3 times square root of 3 over negative 3. So we see that the negatives would cancel, the 3's would cancel. So this is just the square root of 3. So let me get rid of this and slide this down like this. So we know we're going to be in quadrant 3, right? Because this is negative and this is negative. So in other words, from the origin, we're going to the left and then we're going down. So if I go inverse tangent here with square root of 3, I'm going to get something in quadrant 1. So let's key that into the calculator, and I'm going to get 60 degrees here. My answer here is not 60 degrees. Remember, I'm going to go from quadrant 1 to quadrant 3. So I need to add 180 degrees. So 60 degrees plus 180 degrees would give me 240 degrees. The other way you could do that is go into quadrant 3 and find an angle with a reference angle of 60 degrees. So again, it's just 180 degrees plus 60 degrees, which gives you 240 degrees. So either way. So now that we have this set up, we can finally do our multiplication. So I'm going to go 6 times 6, that's 36. And then I'm just going to write CIS, and then 330 degrees plus 240 degrees. That's going to be 570 degrees. And for this one, I would find the coterminal angle. So if I subtract 360 degrees, I will get 210 degrees there for the argument. So of course you can write this as 36 times the quantity cosine of 210 degrees plus I times the sine of 210 degrees. Okay, let's paste this in. So things are given in terms of radians. It's going to be this one here. You can tell because of the 36. I think a lot of you know that 210 degrees is going to convert over to 7 pi over 6. But just for the sake of completeness, we can always do this on the fly. So multiply this by pi over 180 degrees. Forget about the degree units. That's going to cancel. All right, now immediately you can cancel a common factor of 10 and just deal with 21 over 18. Now 21, let's just write it as 7 times 3. And for 18, let's write it as 6 times 3. And I know you could break 6 down further, but it's not going to really do you any good. So let's cancel this with this. And so you get 7 pi over 6. So let's just erase this and erase this. And let's put 7 pi over 6 here and 7 pi over 6 here. So again, the answer is 36 times the quantity, cosine of 7 pi over 6, plus I times the sine of 7 pi over 6. All right, let's take a look at question 12. Here we're asked to simplify and then write in polar form. So let's look at this guy. We have negative, and then we have 3i up here. This is over. You have the square root of 42 over 2, and then minus the square root of 42 over 2 times I. Okay, let's grab this real quick. Let's come down here and paste this in, and let's see what we can do. So I want to write this in polar form first. So what I'm going to actually do is remove this negative from here and put it here. Remember, if you have a fraction negative a over b, this is equal to negative a over b, or it's also equal to a over negative b. So I'm just taking this and transferring it here into the numerator just to make things a little bit more clear in terms of what's going on. So the first thing I would do here is convert this over. So basically, if you have just negative 3i, you could say that's 0 plus negative 3i, or basically 0 minus 3i like this. And so how would we convert this over to polar form? Well, the r value is going to be what? R is equal to the principal square root of, we know that 0 squared is just 0, so forget about that. And then plus negative 3 being squared is 9, so the square root of 9 would be 3. So the r value there is just going to be 3. Now this is times, let's go CIS. For the argument here, just think about the fact that if you're plotting this complex number, you're basically just going to go down by 3 units, okay? So let me just draw a sample coordinate plane here real quick, just so we can think about this. So let's say that this is 1, 2, 3 units down. So this is me plotting that complex number right there. So let me just sketch that real quick as a position vector. So the angle you're going to be looking for is this one right here. And we know that's a 270 degree angle, or you could say 3 pi over 2 if you want to work with radians. The reason you really can't do the inverse tangent here is because this right here is going to be 0. So if you go tangent of theta is equal to, let's say you take your imaginary part, so negative 3 over 0, well, that's undefined. So that's not going to work in this case, so you need to make a little simple sketch. Okay, let's get rid of this. And let's put that this is 270 degrees, or again, you could put 3 pi over 2 in terms of radians. Let me get rid of this, and I can actually slide this over here. Okay, so this will be over. For this one, the r value is equal to the square root of, we have the square root of 42 over 2 being squared, and then plus, you have the negative of the square root of 42 over 2 being squared. Okay, so for this one, this would be 42 over 4. And it's the same in each case. So you have 42 over 4 plus 42 over 4, which is going to give me 84 over 4. And 84 over 4 is 21. So this is going to be the square root of 21. So let's write the square root of 21 and then CIS. For the argument here, again, think about the fact that you're going to the right and then you're going down. So you're going to be in quadrant 4 because this is positive and this is negative. So if I go tangent of theta is equal to, let me put a little border there. We go imaginary over real. Well, this guy divided by this guy, I think we can all see we're going to get -1. And so if you have the tangent of theta equals -1, we know that the inverse tangent function is going to give me -45 degrees. Again, if I'm in quadrant 4, because I went to the right and went down, if I have a theta that's equal to -45 degrees, all I have to do is correct for that and just add 360 degrees so I can find the coterminal angle, and this is going to give me 315 degrees. Okay, so let's put 315 degrees there, like that. Let's get rid of this, and let's put equals here. The first thing we're going to do is our division with these absolute values. So 3 over the square root of 21. I'm going to multiply by the square root of 21 over the square root of 21, and this equals 3 times square root of 21 over 21. And let's cancel a common factor of 3 between numerator and denominator. 3 divided by 3 is 1, and 21 divided by 3 is 7. So this ends up giving me square root of 21 over 7. So let me move this over here. Now, I'm going to go CIS, and then I'm going to subtract this guy minus this guy. So this argument in the numerator minus this argument in the denominator. So 270 degrees minus 315 degrees. That's going to give me -45 degrees. And of course, I would just find the coterminal angle. So if you add 360 degrees, that's going to be 315 degrees. Okay, so I'm going to write this now as square root of 21 over 7 times the quantity. You have the cosine of 315 degrees plus I times the sine of 315 degrees. Okay, I'm just going to paste that in there. And this is the guy that we're going to want for the answer. So you have the square root of 21 over 7 times the quantity cosine of 315 degrees plus I times the sine of 315 degrees. All right, let's take a look at question 13. So here we're asked to simplify. Write your answer in rectangular form. So we're going to have the square root of 3 and then plus I. And this is raised to the 5th power. Okay, let's grab this real quick and let's come down here. So there's a lot of different strategies you could use to figure out the answer here. What I'm going to do is stay consistent with what we talked about in the lesson. I'm going to convert this into polar form first, and then we're going to use our little formula. So the first thing is if I want this in polar form, I need my R value, or the absolute value of this complex number. So that's the principal square root of, you're going to have the real part, which is the square root of 3 being squared, then plus the imaginary part, that's going to be a 1, that's going to be squared. So then square root of 3 squared is 3, 1 squared is 1, so this is 3 plus 1 or 4, and the square root of 4 is 2. So let me put this down here. So this is 2 times the quantity, the cosine of blank, plus I times the sine of blank. Let me close that down, and then let me put some brackets here. Remember, we're going to raise this to the 5th power. Okay, so for this angle, or the argument, as we call it, basically you're going to say that the tangent of theta is equal to, you're going to have the imaginary part, which is 1, over the real part, which is square root of 3. If you rationalize the denominator there, this is going to give you the square root of 3 over 3. So we are in quadrant 1, so you can just use your inverse tangent function. So you can say that theta is equal to, let me get rid of this, the inverse tangent of this square root of 3 over 3. So you can key that into your calculator, but most of you already know that this is going to be 30 degrees, or pi over 6 if you're working with radians. So let's just stick with degrees. So we'll put 30 degrees here and 30 degrees here. Okay, let's get rid of this. All right, so the rule for this guy tells us that basically you want 2 raised to the 5th power. So you could write 32, or let's just write that out later. So we'll put 2 to the 5th power, then times the quantity, the cosine of, you're going to multiply this guy right here by this argument here. So it's going to be 5 times 30 degrees plus I times the sine of, again, 5 times 30 degrees. So this is going to give me 2 to the 5th power is 32, and then times the quantity. So 5 times 30 degrees is 150 degrees. So this is the cosine of 150 degrees, plus I times the sine of 150 degrees. Okay, close that down. I think that at this point in the course, we all know that the cosine of 150 degrees is the negative of the square root of 3 over 2, and the sine of 150 degrees is going to be 1/2. Again, if you don't know that, it's not that big of a deal. So the cosine of 150 degrees, you have a 30-degree reference angle, and you're in quadrant 2, so cosine's negative. So this is the negative of the cosine of 30 degrees. So this equals negative square root of 3 over 2. And then for the sine of 150 degrees, again, you're in quadrant 2, so you're positive. You can put a plus there if you need it. So it's the same thing as the cosine of 30 degrees. Maybe I'll get rid of that and just say that this is 1/2. Okay, so I'm just going to erase this. I think we all know this at this point. Let's get rid of this and say that we're going to have 32 times the quantity. This would be negative square root of 3 over 2. And then plus, this would be 1/2 times I like this. And all you're going to do to finish this up is distribute this guy to each term inside the parentheses. So this would be 32 times negative square root of 3 over 2. And then plus 32 times 1/2 times I. So let's go ahead and cancel this with this and put a 16 here. This with this and put a 16 here. And we'll say this equals, this would be negative 16 times square root of 3, and then plus 16i. So that's going to be my answer. Let's copy this, and let's paste this in. So we're going to scooch down here, and this is the guy that we're looking for. So it's negative 16 times square root of 3 plus 16i. All right, let's take a look at question 14 now. So we want to find all nth roots. Write the answer in polar form. So we have 1 plus I times square root of 3, and here n is equal to 4. So we're trying to find the 4 fourth roots for this complex number. Okay, the first thing I would do is put this into polar form. So you want your r value, which is the square root of, you have 1 squared, which is 1, plus square root of 3 squared, which is 3. 1 plus 3 is 4. So the square root of 4 is going to be 2. So that's your r value. So let's say that this is 2 times, you're going to have the cosine of, for the argument here, again, the tangent of theta is equal to, the imaginary part is the square root of 3, and then that's over the real part, which is 1. So the tangent of theta is equal to the square root of 3. Now we're going to be in quadrant 1, right? This is positive and so is this. So that means I can just do the inverse tangent of square root of 3, and that would be my theta. So theta is equal to this. Let me get rid of that. And maybe that could be a little bit better. So this is equal to 60 degrees, or again, pi over 3 if you want to work with radians. So let's go ahead and put this in terms of radians, because I think that's how our answer is given. So let's say that this is going to be pi over 3. And let's say plus I times the sine of pi over 3. Okay, let's close that down. If we want to find our roots, let me just put a little border here. The first piece of this is you want to take the nth root of your r, okay? So in this case, the n is 4, and so it will be the fourth root of the r is 2, so the fourth root of 2. So let's go ahead and say that this is the fourth root of 2, and then I'm going to abbreviate this and write CIS. The first angle is really easy to get. All you have to do, because of how the formula works, you're going to take that angle, which is pi over 3, and you're just going to divide it by that n. Okay, so I'm going to multiply by 1 over 4, and this is going to give me pi over 12. So the first one is always very simple to get. We are done. Okay, for the next ones, again, you can go back to your formula. When you think about alpha in general, it's equal to, you have theta over n, so we just did that. In this case, that's going to be pi over 12. So this is pi over 12. And then plus, it's 2 pi, so that's 1 full rotation, times the current value for k. So k is going to go up to 1 less than n. So in this case, we would do 0, 1, 2, and then 3. Okay, but you start with 0, and because you're starting with 0, this piece right here is going to go away, and that's how you got that. Okay, so this is over your n, which in this case, n is 4. Let me put that in there. So really the way I think about it is, I don't use this formula. I just say, well, okay, I can reduce this to pi over 2, and then this times k. Well, all I'm really doing is I'm adding pi over 2 to each previous solution. Okay, so that's how I think about it. If you want to key it in each time with that value of k, you can do it that way as well. But personally, I like to do it the other way better. So let's go and just add pi over 2. So we're going to have pi over 12 plus pi over 2. And I'm going to multiply this by 6 over 6. So this would be 6 pi over 12. And if we add these guys together, you're going to get 7 pi over 12. So let me put a comma, and I'll put the fourth root of 2, and then CIS. We're going to have 7 pi over 12. So that's the second guy. So the next guy, you would start with 7 pi over 12. Let me move this down here. So 7 pi over 12. And then plus this 6 pi over 12. Again, that's pi over 2, just getting a common denominator. So this would give me 13 pi over 12. So let me say that this right here would be the 4th root of 2, and then CIS, and then 13 pi over 12. Okay, let me come down here a little bit more. So for the last one, let me say this is the 4th root of 2, and then CIS, I'm going to take the 13 pi over 12, and I'm going to add, again, that pi over 2, and just multiply this by 6 over 6. So this is 6 pi over 12. So 6 pi plus 13 pi is going to give me 19 pi. So this would be 19 pi over 12. Okay, let me get rid of this. So in each case, the absolute value or the modulus for this complex number is the 4th root of 2. The argument is going to be different in each case. So here it's pi over 12, then it's 7 pi over 12, then it's 13 pi over 12, and then it's 19 pi over 12. So this is what we're going to be looking for, this choice D. So let's come down here and select choice D. All right, let's take a look at the quiz. For the first question, we're asked to find the polar coordinates. So when we look at this problem here, you're going to see that the answers are not going to immediately match what you would first think about when you look at this point. So if I think about this guy right here, the angle is 150 degrees at your theta, and you're on a circle with a radius of 6. So it's like I stepped out from the pole to a circle with a radius of 6, and then I rotate myself to 150 degrees. So you could label this as 6, 150 degrees. But looking at the choices, you don't see that, okay? So what we're meant to do is find an alternative form for this point, right? So instead of 6, 150 degrees, what else could it be? Well, remember, you could swing around by multiples of 360 degrees. So in other words, let's say I sketch this in, this is your polar axis, and then this right here, let me make that a little bit better. So this is going to be a ray, and that would be 150 degrees. So this is 150 degrees. Let's say I was starting here, and I swing around 360 degrees, and then by another 150 degrees, well, that would be 150 degrees plus 360 degrees, so that would be 510 degrees. So this would be the same as if I said 6, 510 degrees. It would also be the same if I subtracted 360 degrees away. So that would be negative 210 degrees. So let's say this is 6, negative 210 degrees. So in other words, let me get rid of this. Let's say I started here and I rotated clockwise. So this would be negative 210 degrees. So all of that would locate the same point. I think we know that at this point. Let me get rid of this. Let me get rid of this. You could also do multiples of that. But what's going to happen is, let me just grab this here for reference. Come down here. And I'm just going to paste this in. You don't see any of these. So you have 6, 150 degrees. That does not show up. 6, 510 degrees. You have 510 degrees, but you have negative 6. So that doesn't work. And then you have 6, negative 210 degrees. Well, I have negative 6, negative 210 degrees. So that doesn't work. So what I'm going to do is get rid of this choice right here and this choice right here, because neither of those is going to work, right? 330 degrees, that's not going to work. And 690 degrees, if you added another 360 degrees of 510 degrees, that's 870 degrees. So using a positive 6, you're not going to get any of those answers. So let me get rid of this. And now let's consider negative 6 for the R value. So let's come back over here and let's think about how I can get to this point using a negative R value. So we know already that basically, if you have a negative R value, you're walking backwards, right? Or you're reflecting your point about the pole. So let me first sketch this guy right here. I'm just going to add 180 degrees to 150 degrees, and that's going to give me 330 degrees. So let me sketch that like this, and that's not the best drawing, but we'll just make do with it. And let me go to a circle with a radius of 6. So this right here would be the point 6, 330 degrees, okay? But what I want is this point right here. So what I would do is I would say, I want a negative 6, so a negative 6, 330 degrees. And all that's telling me is that you're just reflecting this point right here across the origin or the pole. So it's just kind of like I located this, and instead of going forwards, I turn around and go backwards by 6 units. So that's all it is. So another way to locate the same thing. So negative 6, 330 degrees. You could also have multiples of 360 degrees added onto that. okay? So you could add 360 degrees or you could subtract 360 degrees. So one way you could do this is to say it's -6 comma 330 degrees plus 360 degrees. That's 690 degrees. And this is going to be an option for us. So let's come down here and say that this is -6 comma 690 degrees. That's going to be our answer. All right, let's take a look at question 2. So we want to convert to rectangular coordinates. So right now we have polar coordinates. So we have -4 and then comma -210 degrees. So this is the r and this is the theta. And to convert over is really, really simple. We say that x is equal to r times the cosine of theta and y is equal to r times the sine of theta. Okay, so real simple. So for r, we know that's -4. So let's just plug in each case. And then for theta, we have -210 degrees. I like to work with the coterminal angle. I just find it easier. So I'm going to add 360 degrees, and that's going to give me 150 degrees. Okay, so we know that cosine is negative in quadrant 2, right? And a 150-degree angle is going to lie in quadrant 2. So I can just say that this has a 30-degree reference angle. So I would want to say this is the negative of the cosine of 30 degrees. So in other words, what you can do over here is just multiply -4 by -1. So this is +4 times the cosine of 30 degrees. And then sine is positive in quadrant 2. So you can just say this is the sine of 30 degrees, okay, because it's going to be the same thing. So the cosine of 30 degrees is going to be square root of 3 over 2. So this is square root of 3 over 2. And the sine of 30 degrees is going to be 1/2. So let's put this like this. So if we multiply, 4 divided by 2 would be 2. So this is 2 times square root of 3. So that's going to be my x coordinate. So it's 2 times square root of 3. And then for the y coordinate, -4 divided by 2 would be -2. So let's just say this is -2 here, and I'll put that in there. So looking through my answers, it looks like I'm going to want this guy right here, where we have 2 times square root of 3 for the x value, and then -2 for the y value. All right, let's take a look at question 3. So we want to convert to rectangular coordinates. So again, we have -4, that's the r value, and then 300 degrees, that is your theta. So what I'm going to do here, again, is just say that x is equal to r, which is -4, times the cosine of theta. So that's 300 degrees. Now, for 300 degrees, that's going to be in quadrant 4. And in quadrant 4, cosine is positive. The reference angle there would be 60 degrees. So let me change this to the cosine of 60 degrees. Okay, this is y is equal to, you have -4, which is the r value, times the sine of 300 degrees. Now, for 300 degrees, again, it's in quadrant 4. Sine is negative in quadrant 4, and the reference angle is 60 degrees. So basically, I'm going to change this -4 into +4 because it's just like I'm multiplying -4 by -1 because sine is negative in quadrant 4. So I'm going to say this is times the sine of 60 degrees, just changing it over and working with the reference angle. Okay, so this guy right here, the cosine of 60 degrees, we know that's 1/2. So this is 1/2, and the sine of 60 degrees, we know that is the square root of 3 over 2. So this becomes -4 over 2, which is just -2. And this becomes 4 cancels with the 2 and gives me 2. So this is 2 times square root of 3. So my coordinates here, in terms of being rectangular, we would have -2. That's the x value. And then the y value is 2 times square root of 3. So looking through here, we're going to have this one right here. So the x value, again, is -2. And the y value is 2 times square root of 3. All right, for question 4, we're asked to convert to polar coordinates. And again, this is a little bit more challenging. So the r value here is going to be greater than 0. And then theta is greater than or equal to 0 degrees, and then less than 360 degrees. So we are given 1/2 as our x value, and then negative square root of 3 over 2 for the y value. So you have 1/2 comma, you have negative square root of 3 over 2. So the first thing is you need your r value. So this is the square root of x squared plus y squared. So let me write this out. So 1/2 squared, then plus the negative of the square root of 3 over 2 squared. So what is this? This is the square root of 1/2 squared. 1 squared is 1, 2 squared is 4. This is 1/4. And then plus this negative goes away. Square root of 3 squared is 3, and then 2 squared is 4. So obviously 1/4 plus 3/4 is 1, and the square root of 1 is 1. So the r value here is going to be 1. So let me put that this would be 1 here. And then what is the theta going to be? Again, you can use tangent of theta is equal to y over x. You have to be careful though here because you're not in quadrant 1, right? This is positive and this is negative. So from the origin, I'm going to the right and I'm going down. So we're in quadrant 4. Theta is in quadrant 4. So let's just keep that in mind. So the y value is negative square root of 3 over 2. And the x value is 1/2. So let me multiply by the reciprocal. So 2 over 1. So this cancels. You get the negative of the square root of 3. So let me go ahead and just use my inverse tangent function with the positive square root of 3. Forget about the fact that it's negative. I'm just going to find the reference angle here and then go into quadrant 4. So punch that into the calculator. And of course, we know that this is 60 degrees. So what angle in quadrant 4 has a reference angle of 60 degrees? Well, it's going to be 300 degrees. So that's what you're looking for, right? You take 360 degrees and you subtract away the reference angle of 60 degrees and you get 300 degrees. So what I'm looking for is this one right here. So 1, 300 degrees. All right, let's take a look at question 5. So we're asked to convert to polar coordinates. So we have r is greater than 0, theta is greater than or equal to 0 degrees and less than 360 degrees. And so we're going to say that we have 3/2, 3 times square root of 3 over 2. So this is given in rectangular coordinates, and we want polar. So first you need the r value, which is the square root of x squared plus y squared. So 3/2 squared plus 3 times square root of 3 over 2 being squared. 3/2 squared is going to be 9/4. So let's write that. And then 3 squared is 9. Square root of 3 squared is 3. 2 squared is 4. So this right here is 9 times 3 or 27 over 4. So 27 over 4. And of course, this becomes 36 over 4, which is 9. And the square root of 9 is 3. Okay, that's my r value. For theta, it's going to be really easy here because you're in quadrant 1, right? So you can just say the inverse tangent of whatever y over x is. So 3 times square root of 3 over 2. Let me put theta is equal to this. And then times, I'm going to take the reciprocal of this, so 2 over 3. So let's cancel this with this and this with this. So this becomes the inverse tangent of the square root of 3, which is going to be 60 degrees. So let me get rid of this and just say that this is going to be 3, 60 degrees. Looking through my choices, it's going to be this one right here. All right, let's take a look at the quiz. For the first question, we're asked to find the distance between the polar points given. We want to round your answer to the nearest thousandth. So we have 1, 180 degrees. And then we have -2, 300 degrees. All right, I'm just going to copy this and I'm just going to paste this in. I already have the formula here. We're just going to plug and chug. We already know where this comes from. So basically, I'm just going to say that the distance is equal to the square root of. Again, you can label this point as r sub 1 theta sub 1, or you could label this point as r sub 1 theta sub 1. It's not going to matter. Just pick one of them and label as r sub 1 theta sub 1. The other one is going to be r sub 2 theta sub 2. So let's say this is r sub 1, this is theta sub 1, and this is r sub 2, and this is theta sub 2. All right, so for r sub 1, it's 1, so we'll put 1 squared. And then plus for r sub 2, it's -2, so -2 squared. Then we have minus 2 times r sub 1 is 1. Then times r sub 2 is going to be -2. Then times the cosine of, so we have theta sub 2 minus theta sub 1. So it's 300 degrees for theta sub 2, 180 degrees for theta sub 1. So 300 degrees minus 180 degrees would be 120 degrees. All right, so let's just do 1 squared. That's going to be 1. -2 squared is going to be 4. All right, for this guy, let's go plus negative. So -2 times 1 is going to be -2. And then times -2, that's going to be positive 4. So let's say that this is going to be plus, you've got 4 times the cosine of 120 degrees. So you would do this first. Now the cosine of 120 degrees, there's a 60-degree reference angle, and the cosine of 60 degrees is 1/2, but you're in quadrant 2 where cosine is negative, so this is times -1/2. So let's go ahead and cancel this 4 with this 2. That'll give me a 2. So 2 times -1 would be -2. So let's just put -2 here. And so basically, you're going to have the square root of 1 plus 4, which is 5, minus 2, which is 3. So this is the square root of 3. Maybe I don't need such a long square root symbol there. We'll just do that. Now, this guy asked us to round. So let's go back up. It said to the nearest thousandth. So if we have the distance is equal to the square root of 3, let's punch that into the calculator. And let's see, I get about 1.73 and then 2. Now I'm rounding to the nearest thousandth, so I'm looking at the next digit, which is a 0. So this guy right here is my decision digit. It falls in the category of 4 or less. So basically I leave this guy alone. Everything else is basically just cut off. So it's going to be 1.732. So looking through, I want this one. So 1.732. All right, let's take a look at question 2. So here we want to find the distance between the polar points given. We want to round your answer to the nearest thousandth. So let me underline that there. Let me just copy this. So negative 3, 90 degrees. I'm just going to label this now. So let's say this is r sub 1 and this is theta sub 1. And then over here we have negative 3, 240 degrees. So let's say this is r sub 2 and this is theta sub 2. Okay, let's just grab this real quick and let's paste this in. Okay. So just plugging into the formula, maybe I'll give myself a little bit more room here. So the distance is equal to the square root of, we know that r sub 1 is negative 3, so negative 3 squared. And then plus, we know r sub 2 is going to be negative 3 as well. So this is negative 3 squared. And then minus 2 times, well, r sub 1 and r sub 2 are both negative 3. So let's just put negative 3 and then negative 3. So negative 2 times negative 3 times negative 3. Let me go plus negative here so that's crystal clear. And then times the cosine of, you have theta sub 2, which is 240 degrees, minus theta sub 1, which is 90 degrees. And 240 degrees minus 90 degrees would be 150 degrees. Okay, let me just get rid of this. All right, so negative 3 squared is going to be 9. So I'm just going to erase this and just put a 9 here and a 9 here. Negative 2 times negative 3 is 6. 6 times negative 3 is negative 18. So let's put minus 18 like that. The cosine of 150 degrees, you have a 30-degree reference angle. The cosine of 30 degrees is square root of 3 over 2. But cosine is going to be negative in quadrant 2. So this is times the negative of the square root of 3 over 2. All right, so let me go plus negative here. Let me cancel this negative with this negative. So negative times negative is positive. 18 divided by 2 is going to be 9. So basically this becomes plus 9 times square root of 3. So let me put this as plus 9 times square root of 3. Okay, so 9 plus 9 is 18. Now, if you were asked for an exact answer, you could simplify this. And let me just do that in case you're curious. So basically, you would go the square root of 9 can be pulled out of here, and 9 is a perfect square. So you can say this is 9 times the quantity. This would be 2 plus, this would be the square root of 3 like this. And then basically, you could write this as the square root of 9 times, let me do this on a different line because that's not going to fit. So let me actually erase this, put this down here. So this is the square root of 9 times the square root of 2 plus the square root of 3. So we know the square root of 9 is 3, and then just times the square root of 2 plus the square root of 3. Let me make that a little bit better there. All right. Now this is something where if you wanted to give an exact answer, this is what it would be. But you can also just punch this into the calculator and get an approximation. So let's just do that real quick. Let's see. I get about 5.79 and then 5, and then the next digit is a 5. So remember, I'm rounding to the nearest thousandth. So this right here is my decision digit, and it's a 5. So that means change this 5 right here into a 6 and then just cut everything else off. So let me actually just grab this real quick, and I'll just paste this in and say that the distance is approximately 5.796. So this guy right there. All right, let's take a look at question 3. So we want to find the distance between the polar points given. Round your answer to the nearest thousandth. All right, let me underline that. So again, I'm just going to write that this is 4, 180 degrees. So let's say this is r sub 1 and this is theta sub 1. And then this one is negative 1, 300 degrees. So this is r sub 2 and this is theta sub 2. Okay, let me grab this real quick. And let me paste this in here. Let me just drag this out of the way. So the distance is equal to the square root of, for r sub 1 we have 4, so this is 4 squared. Then plus for r sub 2 we have negative 1, so negative 1 squared, minus 2 times r sub 1 is 4. And then r sub 2, we're multiplying by that. That is going to be negative 1, and then times the cosine of theta sub 2, that's going to be 300 degrees. Theta sub 1 is 180 degrees. So 300 degrees minus 180 degrees is going to be 120 degrees. Okay, let me get rid of this, just in the way at this point. And basically, we know that the cosine of 120 degrees is negative 1/2. You have a 60-degree reference angle, and you're in quadrant 2, where cosine is negative, right? So cosine of 60 degrees is 1/2. But again, because you're in quadrant 2, it's negative 1/2. Okay, so just crank this out. 4 squared is 16. And then we know that negative 1 squared is going to be 1. So let me put plus negative here. So that's crystal clear that we're going negative 2 times 4, that's negative 8. And then negative 8 times negative 1, that's going to be 8. So this right here would be plus 8, and then times negative 1/2. Okay, so we're going to do this multiplication. So 8 divided by 2 is 4. 4 times negative 1 is negative 4. So let's just write minus 4 here. So now you have 16 plus 1, which is 17. And then 17 minus 4, that's going to be 13. So this is just the square root of 13. Let's just punch that into the calculator. And I get about 3.605. And then I've got a 5 after that. So I'm going to make my decision based on this, and it's a 5. So that means I'm going to move this up by 1. So this is a 6, and then cut everything else off. So let me grab this, and I'm just going to paste this in. Say the distance is approximately 3.606. So this guy right there. All right, let's take a look at question 4. So we want to find the distance between the polar points given. Round your answer to the nearest thousandth. So we're taking a look at 1, 270 degrees, and then we're looking at negative 4, 180 degrees. So let's say this is r sub 1, and this is theta sub 1. Let's say this is r sub 2, and this is theta sub 2. So let me grab this real quick and come down here, paste this in, and I'll say the distance is equal to the square root of. So for r sub 1, that's going to be 1. So we want 1 squared. And then plus for r sub 2, that's negative 4, so negative 4 squared. And then minus 2 times r sub 1, which is 1, times r sub 2, which is negative 4. Then times the cosine of, we have theta sub 2, which is 180 degrees, minus theta sub 1, which is 270 degrees. So 180 degrees minus 270 degrees, that's going to be negative 90 degrees. Okay, let me get rid of this. Now with cosine, you have a negative angle identity that says that cosine of, let's say, negative 90 degrees is equal to the cosine of 90 degrees. So you can just get rid of the negative there. And basically, we'll just say that this is equal to the square root of 1 squared is 1, and then negative 4 squared is 16, so plus 16. And then for this, let's go plus negative here. So negative 2 times 1 is negative 2. Negative 2 times negative 4 is plus 8. And then times the cosine of 90 degrees. Now, hopefully you know that the cosine of 90 degrees is 0. So basically this is 8 times 0, which is going to be 0. So this is just going to go away. So now I have 1 plus 16, which is 17. And let me just erase this and make this a little bit more clean. So the distance is now equal to the square root of 17. And if you want to approximate this, let's just key this into the calculator. And let's say I get about 4.123, and then I have a 1 there. So the 1 falls in the category of 4 or less, so you can just cut that off. And let's just grab this real quick. Let's paste this in and put the distance is about 4.123. So this guy right there. All right, for question 5, we want to find the distance between the polar points given. We want to round your answer to the nearest thousandth. So we have 4, 300 degrees, and then we have 3, 330 degrees. Okay, let's grab this real quick. And let's paste this in. So I'll just say that this is r sub 1. This is theta sub 1. Let's say this is r sub 2. So let me make this a little bit better here. And actually, this could be better. So let's clean that up a little bit. And then this will be theta sub 2. And that doesn't look so good. Okay. So just plug in. Again, I can just slide this down out of the way. So the distance is equal to the square root of. So for r sub 1, we have 4. So this is going to be 4 squared. Plus for r sub 2, we have 3, so this is 3 squared, minus 2 times r sub 1, which is 4, times r sub 2, which is 3, times the cosine of theta sub 2, which is 330 degrees, minus theta sub 1, which is 300 degrees. 330 degrees minus 300 degrees is 30 degrees. So let me just put 30 degrees there. I can get rid of this. And we know the cosine of 30 degrees is going to be the square root of 3 over 2. So I'll just replace that. And let me just go through here now. So 4 squared, we know that's 16. 3 squared, we know that is 9. And basically, you could say this is negative 2 times 4, that's negative 8. And then negative 8 times 3, that's negative 24. So let's put minus 24 here. So minus 24, this is multiplied by square root of 3 over 2. So let's go ahead and cancel this with this and get a 12. And so this right here would be minus 12 times square root of 3. So 16 plus 9, we know that is 25. So what I end up with here is the square root of 25 minus 12 times square root of 3. Now, if I'm looking for an exact answer, this is as good as I can get. But if I want to approximate, again, I could just punch this into my calculator, and I get about 2.053 and then 1. So this guy right here, again, that's your decision digit. So this falls in the category of 4 or less. So I'm just going to cut this off, and this will be my approximation. So let's grab this real quick, and I'll just paste this in. Say the distance is about 2.053. So this guy right there. All right, let's take a look at the quiz. So for the first question, we want to convert to polar form. So here we have y is equal to 5x. So just to convert this over to polar form, what you could do is replace x with r times cosine of theta and y with r times the sine of theta. But it's a little bit easier in this particular case to use the relationship that y over x is equal to the tangent of theta. So I'm just going to divide both sides of the equation here by x, and then I'm going to cancel this away. And so I have y over x, which is the tangent of theta, and this is equal to 5. Now, you see this answer right here, tangent of theta is equal to 5. In some classes, they won't accept that, so you're going to have to actually use the inverse tangent function. But for this one, since we're doing self-study, this would be fine. Now, of course, you could say that theta is equal to the inverse tangent of 5. And if you punch that into your calculator, if you want degrees, let's say you get about 78.69 degrees as an approximation. So we would say theta is approximately 78.69 degrees. And of course, you could do the same thing by adding 180 degrees. So you could say, or theta is approximately 258.69 degrees. So if you answered like this when you were working the problem, this is an acceptable answer. But I think this one's a little bit better in this particular case because when we think about the tangent of theta being equal to 5, well, theta there is not a nice little clean integer like we're used to working with. So you can give your answer like this, or you can give your answer like this. All right, let's take a look at question 2. So here we want to convert to rectangular form. So we have r is equal to -4 times the cosecant of the quantity theta plus pi over 6. Okay, let's grab this real quick, and let me paste this in here. Okay, so first and foremost, we know that the cosecant of theta is equal to 1 over the sine of theta. So we're going to use that relationship to rewrite this. So let's say that r is equal to -4 over, you're going to have your sine of this quantity theta plus pi over 6. So let's come down here and let's think about this. So I would have r is equal to -4 over. For this one, I'm going to use my sum identity for sine. So this is the sine of theta times the cosine of pi over 6. Now we know pi over 6 is going to be 30 degrees, and so the cosine of 30 degrees is square root of 3 over 2. So let me write that this is the square root of 3 over 2, and then you have plus, you're going to have the cosine of theta times the sine of pi over 6. Again, that's 30 degrees. The sine of pi over 6, or the sine of 30 degrees, is going to be 1/2. Now, if you've watched me do this type of problem before, you know that I'm going to factor out a 1/2 here, because you can write the square root of 3 over 2 as the square root of 3 times 1/2. So that means that this right here is common, right? So I can pull it out, and you don't have to do that. It just makes it a little bit easier. So I always do it. So you're going to get r is equal to -4 over, you're going to have this 1/2 times the quantity. You're going to have the square root of 3 times the sine of theta, and then plus your cosine of theta. So a lot of different ways you can go from here. What I would do is multiply both sides by this quantity right here. So that is going to give you r times the quantity, square root of 3 times the sine of theta plus the cosine of theta, and this would be equal to -4 over 1/2. If I divide by 1/2, it's like multiplying by 2, so this is just going to be -8 over here. Okay, so all I'm going to do at this point is just distribute the r to each guy inside, and I didn't kind of make that all the way, so let's do that again. So let's come down here and say that this would be the square root of 3 times r times the sine of theta, plus you'd have r times the cosine of theta, and this equals -8. So r times sine of theta is y. Let me just erase this and put this in here so we can save some space. So this is y. R times cosine of theta is x. The way the answers were given, we had this in terms of slope-intercept form, so it's solved for y. So what I would do is divide everything by the square root of 3, and this is going to get a bit messy because you have to rationalize the denominator, but we're just going to cancel this with this. We'll say that y plus, we'll go 1 over the square root of 3, and I'll rationalize and say times the square root of 3 over the square root of 3, and then times x is equal to, we'll go negative 8 over the square root of 3, and then times the square root of 3 over the square root of 3. So let's say this is y plus, this would be the square root of 3 over 3 times x, and then this would be equal to, you'd have the negative of 8 times square root of 3 over 3. Now let me grab this real quick, and let me paste this in here. It needs to be solved for y, so the last step I'm just going to subtract this guy away from each side of the equation. So let's say we would have y is equal to the negative of the square root of 3 over 3 times x, and then you have minus 8 times the square root of 3 over 3. So that's what we're looking for. So let me cut this. So let me paste this in, and it's going to be this one right here. So y is equal to the negative of, it's written a little bit differently, so you have x times square root of 3 over 3, so it's the same thing as this, and then minus 8 times square root of 3 over 3. So that's our answer. All right, for question 3, we're asked to convert to rectangular form. So we have r is equal to the negative of the secant of theta. So let's grab this real quick, and let's paste this in. So let's think about this. The secant of theta is going to be 1 over the cosine of theta. So let's say that this is r is equal to negative 1 over the cosine of theta. You could just multiply both sides by the cosine of theta. And so you would have r times cosine of theta is equal to negative 1. R times cosine of theta is x. So this is just x is equal to negative 1. So it's just a vertical line. So let's come up here and say x equals negative 1. All right, let's take a look at question 4. We want to convert to rectangular form. So we have r is equal to the negative of the cosecant of this quantity theta plus pi over 6. So let's grab this real quick, come down here, and let's paste this in. Okay, so for this one again, if you think about the cosecant of theta, it's going to be 1 over your sine of theta. So let's say that this is r is equal to, I'm going to write this as negative 1 over the sine of this quantity theta plus pi over 6. So again, pi over 6 is 30 degrees. If you want to work with degrees, that's fine. So let's say this is r is equal to negative 1 over, you're going to use your sum identity for sine. So we're going to have the sine of theta and then times the cosine of pi over 6. I think we all know that's square root of 3 over 2. I'm going to write this as the square root of 3 times 1/2. And you'll see why in a moment. We're going to end up factoring out a 1/2. So then I'm going to put plus, you're going to go cosine of theta times the sine of pi over 6. Now the sine of pi over 6 is a half. Again, the reason I broke this up like this is that we are going to factor out this 1/2 here. So we'll say that r is equal to, you have negative 1 over, pull the 1/2 out in front of some parentheses, and inside you're going to have the square root of 3 times your sine of theta, and then plus your cosine of theta. So let me close that down. Now there's a lot of ways you can proceed. I'm just going to multiply both sides by this quantity right here, so I can clear that part of the denominator. So you would have r times the quantity, square root of 3 times the sine of theta, and then plus the cosine of theta, and this equals negative 1 over 1/2. So again, if you're dividing by a half, it's the same thing as multiplying by 2. So this is basically just going to be negative 2. Okay, so thinking about this now, we're just going to distribute the r to each guy inside the parentheses. So you would have the square root of 3 times r times the sine of theta, and then plus r times the cosine of theta, and this would be equal to negative 2. Well, r times the sine of theta is y, so this is square root of 3 times y, and then plus r times the cosine of theta is x, and this equals negative 2. Now, if you want to solve this for y, you're going to divide everything by square root of 3, and you're going to also have to move this over. Whatever order you want to do it in, it doesn't matter. Let's just subtract x away from each side first. So let's say this is the square root of 3 times y is equal to negative x minus 2, and then I'll divide everything by the square root of 3. And let's see what that is going to work out to be. So we know that this is going to cancel. So y is equal to, let's write this as negative 1 over the square root of 3. If I multiply by the square root of 3 over the square root of 3, this is the negative of the square root of 3 over 3. So let me write that. So the negative of the square root of 3 over 3, and then times x. Sometimes you put the x up there. It's really whatever you want to do. And then minus, let's go 2 times square root of 3 over 3. Because I would just multiply this by the square root of 3 over the square root of 3. So 2 times square root of 3 is where I get this part from, and square root of 3 times square root of 3 is 3. So let me get rid of this. And this would be our answer in slope-intercept form. So let's copy this, paste this in here, and let's look at what we have. So y equals the negative of x times square root of 3 over 3. So again, you could move that up here if you wanted to. And then minus, you have 2 times square root of 3 over 3. So this is the answer that we want. All right, let's take a look at question 5. So again, we're asked to convert to rectangular form. So we have r is equal to the cosecant of this quantity theta plus 45 degrees. So let's grab this real quick and let's paste this in here. So again, when we think about the cosecant of theta, it's 1 over the sine of theta. So we would just say this is r is equal to 1 over your sine of this quantity theta plus 45 degrees. Let me make that a little bit cleaner there, and I'll extend this a little bit. So let's say this is r is equal to 1 over. So again, use your sum identity for sine, the sine of theta, so the sine of theta, and then times the cosine of 45 degrees. And then this is plus, you're going to have your cosine of theta, and then times the sine of 45 degrees. Now the cosine of 45 degrees and the sine of 45 degrees, in each case that's the square root of 2 over 2. So let me just erase this and put that this is the square root of 2 over 2, and this is the square root of 2 over 2. Maybe I can make that a little bit better there. And so this would get pulled out, right? So I'm going to factor this out since it's common to both. So let me come down here, and we will just say that r is equal to 1 over. You have your square root of 2 over 2 times the quantity sine of theta plus cosine of theta. And then from here, you can multiply both sides by sine of theta plus cosine of theta. So this is going to give me r times the quantity sine of theta plus cosine of theta is equal to 1 over square root of 2 over 2. So for this, since you have 1 divided by this guy right here, all you really have to do is take the reciprocal of this guy, so 2 over square root of 2. So 2 over square root of 2. So I'm going to rationalize the denominator, so times the square root of 2 over the square root of 2. So this is 2 times square root of 2 over 2. So 2 times square root of 2 over 2. And of course, you can cancel a common factor of 2 between numerator and denominator. So this is just the square root of 2. Okay, let's come down here. We know that r times sine of theta is y. And we know that r times cosine of theta is x. But let me show that in case you're lost. So this is r times sine of theta, then plus r times cosine of theta. And this equals square root of 2. So this equals square root of 2. And if you want to write this in slope-intercept form, just subtract x away from each side. So y is equal to negative x plus the square root of 2. So let's grab this, paste this in. So you have y is equal to negative x plus square root of 2. So this guy right there. All right, let's take a look at the quiz. For question 1, we're asked to convert to polar form. So we have this x minus 6 quantity squared. And then plus we have this quantity y plus 4 squared. And this equals 52. Okay, let's grab this real quick. And we'll paste this in here. Now, there's a quick way to do this and a long way to do this. Either way, it's really not that time consuming, so I'll just do it both ways for you. The first way is the long way, and basically you would just expand this and expand this. And so if I use my special products formula, I'm going to square the first guy, so this is x squared minus 2 times this guy, so basically minus 12x, and then plus this guy 6 squared, so 36. Then plus over here, same pattern, so y squared plus you're going to have 8y, and then plus 16. So the first guy squared plus 2 times this guy, so 2 times 4 is 8 times y is 8y, and then plus the last guy, which is 4 squared, that gives you 16. So this is equal to 52. Now, if you do 36 plus 16 in your calculator, you're going to get 52. So let me actually erase this from here and put this as 52. So let me subtract 52 away from each side. So that's going to cancel and put a 0 over there. Now what you see is that you have x squared minus 12x plus y squared plus 8y equals 0. So let me actually clean this up a little bit. And we're going to reorder some things. So I'm going to put x squared and y squared next to each other. So x squared plus y squared. And then I'm going to go minus 12x and then plus 8y, and this equals 0. When we work with converting over to polar, x squared plus y squared is going to be converted to r squared. So this is r squared. And then minus 12 times, when you think about x, it's r times cosine of theta. So r times cosine of theta, and plus 8 times for y, it's r times the sine of theta, and this equals 0. Okay, so at this point, what you'd want to do is get r by itself. Now, you have r squared here, you have r here, and you have r here. So what you're going to do is you're going to say that this is r squared is equal to, I'm going to add this to both sides. So I'm going to have 12 r cosine of theta, and I'm going to subtract this away from each side. So minus 8 r sine of theta. Now, where everyone makes a mistake in the conversion, you see that you have r squared, and they want r by itself, so they take the square root of each side. What you actually want to do is pull the r out, or factor it out, and then divide. So you're going to have r squared is equal to r times the quantity 12 times the cosine of theta minus 8 times the sine of theta. Divide both sides by r. And then r squared divided by r would be r to the first power. And then this would cancel with this. And so you have your r is equal to 12 times the cosine of theta minus 8 times the sine of theta. So let me grab this real quick. And I'm just going to paste this in here. And looking through the answers, it looks like I want this one right here, which is A. So r equals 12 times cosine of theta minus 8 times sine of theta. Now, there's another way to do this. So let's go back and let's just use the shortcut in case you got tripped up using that. So again, when you think about this, this matches the pattern of x minus a, quantity squared, plus this y minus b, quantity squared, is equal to a squared plus b squared. So when you're in this section of trigonometry, you're going to get this type of equation all the time because it works out quite nicely in polar. So this right here converts over to r is equal to 2a times the cosine of theta and then plus 2b times the sine of theta. So if you remember this and you know how to match things up, you can basically do this really quickly. So here you have minus a, here you have minus 6. So a is 6. So a is equal to 6. And then here you have minus b, but here you have plus a 4. So you have to actually change this into minus a negative, okay? So this has to match up completely, so b is going to be negative 4. And then you just plug into this formula. So r is equal to 2 times a is 6, so that's 12, times the cosine of theta. And then basically you have plus 2 times b is negative 4. So let's write minus, your 2 times 4 is 8, and then times your sine of theta. So grabbing this and coming back, you see you get the same thing, right? But it was way, way quicker. So if you want to use the formula, if you can have it memorized, you're going to be good to go. The only thing you have to check, and we didn't really do that here, is to make sure that your a squared plus your b squared does give you this value over here. So in other words, I would check that 6 squared, which is 36, plus negative 4 squared, which is 16, does equal 52. And 36 plus 16 is 52. So basically we know this is the right answer. R is equal to 12 times cosine of theta minus 8 times sine of theta. All right, let's take a look at question 2. So again, we're asked to convert to polar form. So we have this quantity x plus 7 being squared, and then plus this quantity y plus 3 being squared. And then this is equal to 58. Okay, let's grab this real quick and let's come down here. Again, 2 different ways you could do this. You could expand things and then go through the process where you solve for r. That's one way. It takes a little bit of time. And then the other way is just to match things up and use the formula. Let's just do it both ways just so we get some practice. So if I expand this, this is x squared plus 2 times x times 7, so that's 14x, and then plus 7 squared is 49. And then plus over here, we'd have y squared plus 2 times y times 3, which is 6y. And then plus 3 squared is 9, and this equals 58. So 49 plus 9, notice that's 58. So I'm actually just going to erase this and put this as a 0. So let me get rid of this and this. And now what I'm going to do is say that x squared plus y squared is r squared. And I'm going to say this is equal to, I'm going to subtract this away from each side, so minus 14x. I'm going to subtract this away from each side, so minus 6y. All you'd have to do is say that x is r times cosine of theta, and y is r times sine of theta. Let me actually do that real quick. So this is r times cosine of theta, and then minus 6 times r times the sine of theta. Let me make that theta a little bit better. So just factor the r out. And so I'll say that r squared is equal to r times the quantity, negative 14 times the cosine of theta, and then minus 6 times the sine of theta. And let me erase this. And we're going to divide both sides of the equation by r. So this cancels, and then one of these would cancel. So you get r is equal to negative 14 times the cosine of theta minus 6 times the sine of theta. Okay, let me get rid of this. And we'll go select the answer real quick, and I'll come back and do the shortcut. So let's paste this in here. So I am looking for this one down here. So r is equal to negative 14 times the cosine of theta minus 6 times the sine of theta. So that's the answer. So coming back, again, if you want to use the shortcut, it's pretty easy. So we would say that x minus a quantity squared plus y minus b quantity squared is equal to a squared plus b squared. Now you always want to check to make sure this works out before you use the formula. And again, you want to rewrite things to where you have a minus sign. So this would be minus a negative, and this would be minus a negative. That way you can match up this and this. So a here is negative 7, and b here is going to be negative 3. So just check that real quick. Negative 7 squared is 49. And then negative 3 squared is 9. 49 plus 9 is 58, so this is good to go. So you would convert this over into r is equal to 2 times a is negative 7, and then times the cosine of theta, and then plus 2 times b is negative 3, so minus 6 times the sine of theta. So this becomes negative 14 here. So we get the same thing. R equals negative 14 times cosine of theta minus 6 times sine of theta. So coming back up, r equals negative 14 times cosine of theta minus 6 times sine of theta. All right, let's take a look at question 3 now. So we want to convert to rectangular form. So we have r is equal to 2 times the cosine of this quantity. We have theta plus pi over 3. So let's grab this real quick and let's paste this in. So if you want to use the formula here, you do need to clean this up first. So you need to use your sum identity for cosine to do that, so that you can get it into the form of r equals 2a times cosine of theta plus 2b times sine of theta. So let's go ahead and say r is equal to 2 outside of some brackets. And I'm going to use this sum identity for cosine. So the cosine of theta times the cosine of pi over 3. Let's just replace that now. The cosine of pi over 3. We know that pi over 3 is basically 60 degrees. So this is 1/2. And then basically you're going to have minus the sine of theta times the sine of this pi over 3. And we know that the sine of pi over 3 is square root of 3 over 2. So this is square root of 3 over 2. Let's close that down. You're going to distribute this 2 into each guy. So r is equal to, we know that 2 times 1/2 is going to be 1. So let's just write cosine of theta. And then basically minus 2 times square root of 3 over 2. The 2's would cancel. So you're just going to have the square root of 3 times the sine of theta. So this is what you're looking for if you want to use the formula. So r equals 2a times the cosine of theta, then plus 2b times the sine of theta. You do have to make sense of things though, because this 2a here is equal to what? Well, it's equal to 1. 1 times cosine of theta is cosine of theta. And then 2b is equal to this negative of the square root of 3. So you do have additional work to get a and b. So we would say that 2a is equal to 1, divide both sides by 2, and you get a is equal to 1/2. Then for b, we would say that 2b is equal to the negative of the square root of 3, divide both sides by 2, this cancels, and you get b is equal to the negative of the square root of 3 over 2. Okay, let's get rid of this. Now, once you have these guys, you can just plug in, right? So you can say that x minus a, so a is 1/2, so x minus 1/2, quantity squared, and then plus, you have y minus b. So here's where you might make a sign mistake. This is a negative value. The formula has a minus baked into it, okay? So minus a negative is plus a positive. So many people make mistakes on that, it's not even funny. So you want to put plus the square root of 3 over 2, and this is quantity squared, and this equals, now you've got to square this guy plus this guy squared. So 1/2 squared is 1/4, and then the negative would go away if you squared this. Square root of 3 squared is 3. 2 squared is 4, so 1/4 plus 3/4 is going to be 4/4 or 1. So this is what you're looking for. So let's go ahead and grab this real quick. And I'm just going to paste this in and look for this. So it looks like actually it's going to be the first guy here. So we have the quantity x minus 1/2 squared plus the quantity y plus square root of 3 over 2 squared is equal to 1. Now I'm going to show you this using the completing the square method. If you don't care, you just want to figure out what was the answer, then you could just move on. But essentially, a lot of people want to get practice with this. So what you would do is think about the fact that if you could get r squared over here, that's x squared plus y squared. If you could get r times cosine of theta, that's x. And if you could get r times sine of theta, that's y. To do that, I would just multiply both sides by r. So I would say this is r squared is equal to r cosine of theta minus square root of 3 times your r sine of theta. Now, this is x, this is y, this is x squared plus y squared. So let's say that this is x squared plus y squared is equal to your x minus the square root of 3 times y. Okay, so what do I do from here? We know in rectangular form, you want x minus some number, quantity squared, plus y minus some number, quantity squared, is equal to your radius squared. So how do we get that? Well, you're going to move these terms over here, and then you're going to complete the square so that you have a perfect square trinomial, which factors into a binomial squared. So subtract x away from each side. You're going to have x squared minus x, and then plus, I'm going to leave a space, and then plus y squared. I'm going to add square root of 3 times y to both sides. So plus square root of 3 times y, and then plus a blank. And this equals, this would be 0 because this stuff got moved. So sliding down here, again, to complete the square, you always think about the coefficient on your variable raised to the first power. So here it's a -1. So -1, you cut it in half or you divide by 2, and then you square that. So this would be positive 1/4. So this is 1/4, and then this is 1/4. You've got to add it to both sides to make it legal. You're going to use this right here when you factor. So x minus 1/2 quantity squared. So this is going to be x minus 1/2 quantity squared. And then plus over here, you're going to cut this in half. So square root of 3 divided by 2, and then square that. This would be 3/4. So plus 3/4, and then 3/4 here. So 1/4 plus 3/4, we already know that that is 1. And you're going to use this right here inside the parentheses to factor. So y plus square root of 3 over 2. So y plus square root of 3 over 2. This is quantity squared, and this equals 1. So again, it's the same answer that we got. The quantity x minus 1/2 squared plus the quantity y plus square root of 3 over 2 squared is equal to 1. Just a lot more work and a lot more tedious because you have to complete the square. All right, for question 4, again, we're asked to convert to rectangular form. So we have this r is equal to 4 times the sine of this quantity theta plus pi over 3. So let's grab this real quick and let's paste this in. So again, if you get something like this, you have to clean it up first with your sum identity for sine. So let's say r is equal to 4. Inside the brackets, I'll say this is the sine of theta times the cosine of pi over 3. And then plus, you're going to have the cosine of theta times the sine of pi over 3. So we know that the cosine of pi over 3, again, pi over 3 is 60 degrees. This is a half. The sine of pi over 3 is square root of 3 over 2. So let me just write that this is 1/2. And let me write that this is the square root of 3 over 2. Maybe I can make that square root symbol a little bit more legible. And then let me distribute this 4 into each guy here. So r is equal to, 4 times a half is 2. So this is 2 times the sine of theta. And then plus 4 divided by 2 would be 2. So this is 2 times square root of 3 times cosine of theta. Now, here's where you need to be extra careful. When you get problems where your sign is in front, when you use your formula, remember it's given r is equal to 2a times cosine of theta plus 2b times sine of theta. I've seen students on a test match things up and not pay attention and say, well, 2a is equal to 2, and then 2b is equal to 2 times square root of 3. You have to be careful about how the formula is given. So I would reorder this and say that r is equal to 2 times square root of 3 times cosine of theta, and then plus 2 times the sine of theta. Let me get rid of this. And let me drag this up here. And so now you're going to match things up. So 2a is going to be equal to 2 times square root of 3. 2b is going to be equal to 2. So let's get those values real quick. So we'll say 2a is equal to 2 times square root of 3. Divide both sides by 2. And so this would cancel. This would cancel. So a is going to be the square root of 3. So let's write that a is equal to the square root of 3. And then for this one, 2b is equal to 2. Divide both sides by 2. This cancels. You get b is equal to 1. Right? Let me cancel this and put a 1. So b is equal to 1. So what do we get? We get the quantity x minus a, so a is the square root of 3 squared, and then plus the quantity y minus b, b is 1 squared, and this equals your a squared plus your b squared. So square root of 3 squared is 3, and then plus 1 squared is 1, so 3 plus 1 is going to be 4. And this is what we're looking for. So let's grab this. And this is the one that I want. It's going to be C. So the quantity x minus the square root of 3 squared plus the quantity y minus 1 squared is equal to 4. Okay, in case you want to do this by completing the square, once again, you want to multiply both sides by r. Let me actually do this a different way. Things is a little bit easier. So let me write r minus 2 times square root of 3 times cosine of theta. And let me go minus 2 times sine of theta, and this is equal to 0. Now, if I multiply everything by r, this right side would still be 0, and this would be r squared, and then minus 2 times square root of 3 times r times cosine of theta, and then minus 2 times r times the sine of theta. And then, of course, let me make this theta a little bit better. And then the r squared is x squared plus y squared. But actually, let me write this a little bit differently. Let me put x squared here, and then r times cosine of theta, we know that's x. So let me go minus 2 times square root of 3 times x, and then plus blank. And then you'd have a y squared, so let me put plus y squared. And let me put minus 2, r times sine of theta is y, and then plus blank, and then this is going to be equal to 0. I think maybe this is a little bit easier, but maybe it's a little bit more confusing. So however you want to do it, however many steps you need. I know completing the square is a little bit tough, but I like to set it up this way. That way this side is 0 and it's not so confusing when you're adding things and subtracting things away from each side. So let's come down here, and let's say that I'm going to cut this in half and cut this in half, and then I'm going to square those guys. So in other words, I'm going to have negative 2 times square root of 3 over 2 squared. And over here, I would have negative 2 over 2 squared. So this guy right here, the 2's would cancel. The negative of the square root of 3 squared is going to be 3. So I'm adding 3 here, and I've got to add 3 over here. And then basically over here, this would cancel, be a negative 1. Negative 1 squared is 1, so we can add that here and then add that here, so this is going to be 4. So let me clean this up. You want to take this negative square root of 3, that guy that's being squared, so what's inside the parentheses here, that's what you're going to use the factor. So x minus the square root of 3, so this is quantity squared. And then over here, it's plus, what did you end up with here? You ended up with a negative 1 inside the parentheses, so that's what you're going to use the factor. So we're going to say this quantity, y minus 1 being squared, and this equals 4. So either way, you would get the quantity x minus square root of 3 squared plus the quantity y minus 1 squared is equal to 4. All right, let's take a look at problem 5. We're asked to convert to rectangular form. So we have r is equal to 6 times the sine of this quantity theta plus pi over 6. Okay, so again, you got to clean this up first. So r equals 6 times inside of brackets. We're going to do our sum identity for sine. So the sine of theta times the cosine of pi over 6, which is going to be square root of 3 over 2. And then you're going to have plus, you're going to have the cosine of theta times the sine of pi over 6, which is 1/2. We are going to distribute this 6 to each guy here. So the 6 would cancel with the 2 in each case and give me a 3. So basically you're going to have r is equal to 3 times the square root of 3 times the sine of theta. And then plus, this would just be 3 times the cosine of theta. Now again, because of the way the formula is laid out, I would switch this and say this is r is equal to 3 times the cosine of theta plus 3 times square root of 3 times the sine of theta. It's just really easy to make a mistake because the formula is given as r is equal to 2a times the cosine of theta plus 2b times the sine of theta. So this right here is going to get matched up with this right here. And this right here is going to get matched up with this right here. So we're going to say that 2a is equal to 3. Divide both sides by 2. So a is going to be 3/2. And we're going to say that 2b is equal to 3 times square root of 3. Divide both sides by 2. And we're going to say that b is equal to 3 times square root of 3 over 2. Okay, let me get rid of this and get rid of this. And let me slide this over here. And we're just going to say that x minus a, so 3/2, quantity squared, plus we're going to have y minus b, which is 3 times square root of 3 over 2, quantity squared, is equal to, again, you've got to square this guy and then add that to the square of this guy. So 3/2 squared is going to be 9/4. And this guy, we've done it already. So basically, we know it's going to be 27/4. But let's just do it the long way in case you're lost. 3 squared is 9. The square root of 3 squared would be 3. And then 2 squared is 4. So this is 27/4. And if you add 9 plus 27, you get 36. And then 36 over the common denominator of 4 would be 9. So let me get rid of all of this. This would be your rectangular form. And just sliding down. And it looks like I need to slide down a bit to get to what I need. which is this one right here. So answer D. So x minus 3/2 quantity squared plus the quantity y minus 3 times square root of 3 over 2 squared is equal to 9. Okay, one more time just to do this in case you want to complete the square. We're going to multiply both sides by r. So let me do it this way again. So r squared is equal to 3r cosine of theta plus 3 times square root of 3 times r times the sine of theta. So we know this is x squared plus y squared is equal to 3x plus 3 times square root of 3 times y. So again, r squared is x squared plus y squared, r cosine of theta is x, r sine of theta is y. You're going to subtract this away from each side and this away from each side, so the right-hand side would be 0. So x squared minus 3x plus blank plus y squared minus 3 times square root of 3 times y plus blank is equal to 0. So in each case, you're looking to take your coefficient for your variable raised to the first power, cut it in half, and square it. So this is negative 3/2 being squared, so we know that's 9/4. So you're going to put that here, and you're going to put that over here. So this is 9/4 now. If you factor this, this is x minus 3/2 quantity squared. So get rid of this. Over here, you're going to take this negative 3 times square root of 3 over 2, and then you're going to square that. And again, we already know that this gives us 27/4. So 27/4, and let's put that over here. So this gives me 36/4, which is 9. And then to factor this, I know that I just take this inside the parentheses. So basically, I'm going to have y minus 3 times square root of 3 over 2, like this, quantity squared, and this equals 9. So whatever you want to do, this is the rectangular form. It's the quantity x minus 3/2 squared plus the quantity y minus 3 times square root of 3 over 2 squared is equal to 9. All right, let's take a look at the quiz. For the first question, we're asked to find the inclination of the line theta. We are given 8x minus 5y is equal to negative 20. So the first thing is we need to figure out the slope of the line. You could solve it for y if you want. But again, if you have this in the form of ax plus by is equal to c, well, the slope m is going to be negative a over b. And that comes from me solving this for y and then looking at the coefficient for x. So let me get rid of this. We know that a here would be 8. It's the coefficient for x. So this would be negative 8 here. And then b is the coefficient for y. You could say that that's a negative 5. So let me put a negative 5 down here. So negative over negative is positive. So the slope m is going to be 8/5. Okay, so let me get rid of this. And actually, I'll just erase this and write it up here. So m, the slope, is equal to 8/5. Now what we do here is use the formula. The tangent of theta is equal to m. So I can just plug in for m. M is 8/5. And then you can just use your inverse tangent function. So remember, if the argument is positive, you're good to go. Because basically this is going to give you an angle that's in quadrant 1, the acute angle that you're looking for, because this is a positively sloped line. So all we're going to do is say that theta is equal to the inverse tangent of 8/5. And let me get rid of all of this. We know where that came from. I'll just move this up here. This is something we're going to key into our calculator. So this is approximately what? I get about 57.9946. Let's just say 57.99 degrees. So 57.99 degrees. So looking through my choices, I want theta is about, or approximately, 57.99 degrees. All right, let's take a look at question 2 now. So once again, we're asked to find the inclination of the line theta. So here we have x plus 7y equals 28. Let me put a 1 there. Again, if you're given something as ax plus by equals c, well, the slope m is equal to negative a over b. You can solve it for y if you want, but this is just a shortcut if you get it in this form. So a here is 1. It's the coefficient of x, so this would be negative 1. And then b here is 7. It's the coefficient of y. So basically, your slope is negative 1/7. All right, let's get rid of this. We don't need it. So now, because this is negative here, this is going to mean that we have a negatively sloped line and we have more work to do. If we use our inverse tangent function, remember, we have to put a correction in because it's going to give us something in quadrant 4 that's rotating clockwise. So you have to add 180 degrees to that to swing yourself back around and get the angle you want in quadrant 2. This is going to be an obtuse angle. So what we want to do is say that the tangent of theta is equal to m. And of course, m is negative 1/7. So like that. And then basically, I'll just say that theta is equal to the inverse tangent of this negative 1/7. And then I'm going to add to this 180 degrees to correct. Or, of course, if you want to work with radians, you could do pi radians. That's up to you. So let's key this into the calculator. So first, I'm going to get this part. So I'm going to say this is approximately, I get about negative 8.1, let's say 3. So negative 8.13 degrees. So I'm going to add 180 degrees to that. And so if I do that in my calculator, I get 171.87 degrees. Let me erase this and just put this as 171.87 degrees. So again, this is an estimate or an approximation. So theta is about or approximately 171.87 degrees. All right, for question 3, we are asked to find the acute angle theta between the lines. So we have negative 2x minus y is equal to 13. And then we have negative 3x minus 8y is equal to 13. Again, you can find your slope when it's in the form of ax plus by equals c, and the slope is negative a over b. So for this one, let's call it m sub 1. Again, it doesn't matter how you label this. This, let's say it's equal to negative, a here is negative 2. Let me write this out so nobody's lost. So negative a over b. Here a is negative 2. So this is the negative of negative 2. That'll, of course, change into positive 2. And then b is the coefficient for y. Here, let's write that as negative 1. So let's put this down here as negative 1. Well, the negative of negative 2 is 2. And 2 divided by negative 1 is going to be negative 2. So that's your slope there. Then for this guy, m sub 2, let's call it, the formula again is negative a over b. And a here is negative 3. So this is the negative of negative 3. Be very careful there because a lot of people with the negative a over b, they see that this is negative and they just throw that in there. Got to make sure you go the negative of whatever this is. Then b is going to be negative 8. So let's put that down here. And basically the negative of negative 3 is positive 3. And so this here would be negative 3/8. That 3 could be a lot better. And thinking about the formula, hopefully you have that written down, but basically you would say the tangent of theta is equal to, you're going to use the absolute value bars here, and we'll say that it's m sub 2 minus m sub 1 over 1 plus, you're going to multiply these together. So m sub 1 times m sub 2. Let's close that down like that. All right, so I'm just going to plug in. For m sub 2, it's negative 3/8. And for m sub 1, it's going to be negative 2. So minus a negative 2 is plus 2. M sub 1, that's going to be negative 2. And then m sub 2, that's going to be negative 3/8. All right, so to get a common denominator here, I'm going to multiply this by 8 over 8. So that would give me 16/8. So 16/8. And then 16 plus negative 3, or you could do negative 3 plus 16. It doesn't really matter. That's going to give you 13. So this is 13/8. So 13/8. Down here, negative times negative is positive. So let me actually just get rid of these negative symbols. And then 8 divided by 2 would be 4. So basically this becomes 1 plus 3/4. You could write 1 as 4/4. So 4/4. And 4 plus 3 would be 7. So this would be 7/4 right here. So 7/4. Everything is positive. So you could just drop the absolute value bars and just say this becomes 13/8 times the reciprocal of this, which is 4/7. Actually, I'm just going to get rid of this. So let me go ahead and say that 8 divided by 4 would be 2. So I'll put a 2 down here and a 1 up here. Nothing else I can really do. 13 times 1 is 13. This would be over 2 times 7, that's 14. So let me get rid of this. Now, the great thing about this formula is we have a positive argument that's going to go into our inverse tangent function. So we don't have to worry about issuing any correction or anything like that. We just go ahead and take whatever we get. So we say the inverse tangent of this 13 over 14. Remember, we're looking for an acute angle. So we want something in quadrant 1. And that's exactly what we're going to get here because this argument is positive. So let's key this into the calculator. And I get about 42 point, let's say 88 degrees, just rounding to the nearest hundredth. So looking at my answers, I want this one. So theta is approximately 42.88 degrees. All right, let's take a look at question 4. So again, we're asked to find the acute angle theta between the lines. So we have 2x plus 2y is equal to 0. And we have 11x plus 7y is equal to negative 40. So for the first guy up here, we're going to say that the slope m sub 1 is equal to, again, negative a over b. So a is the coefficient for x, so this is going to be negative 2. And b is the coefficient for y, so this is going to be positive 2. So negative 2 over 2 is negative 1. All right, so then m sub 2, again, I'm going to use the same formula. So this is negative a over b. And so a here is going to be 11. So this is negative 11. And b here is 7. So this is 7. Okay, let's get rid of these equations. We don't need them. Just going to plug into that formula. So the tangent of theta is equal to the absolute value of, you have m sub 2 minus m sub 1. And then this is over 1 plus m sub 1 times m sub 2. So let's just plug in what we have here. So for m sub 1, it's a negative 1. So minus the negative 1 is plus 1. Now for m sub 2, that's going to be negative 11 sevenths. So negative 11 sevenths. Let me just write 1 as 7 over 7 now and get that out of the way. Now down here, notice that you'd have a negative times a negative, which would be a positive. And also this, forget about the fact that it's negative 1. Let's just treat it as 1 because we know that the answer from the multiplication or the product there is positive. So really, I can just throw in a positive 11 sevenths. Hopefully that wasn't too confusing. All I'm saying is that negative 1 times negative 11 sevenths is going to end up being 11 sevenths, right? So I'm just throwing that in there now. So we can get rid of this. We don't need this information anymore. And of course, I can write 1 as 7 over 7. Okay, so looking at this, you would have negative 11 plus 7, which is negative 4. So this would give me negative 4 sevenths. So negative 4 sevenths. And down here, 7 plus 11 is 18, so this would be 18 sevenths. So 18 sevenths. Now, we have these absolute value bars here. Let me delete them, and actually what I'm going to do is just make this a positive. So this becomes 4 sevenths times, flip this, 7 over 18. Let me actually get rid of this, and I'm going to cancel this 7 with this 7. And I'll put a 1 here and a 1 here. And then between 18 and 4, you have a common factor of 2. So 18 divided by 2 is 9. 4 divided by 2 is 2. So if I multiply now, this would be 2 in the numerator over 9 in the denominator. So the tangent of theta is equal to 2/9. Okay, so again, because we have those absolute value bars, we end up with a positive argument when we end up doing our inverse tangent function. So this is going to give us something in quadrant 1. So we're going to get the acute angle that we're looking for. So we'll say that this is approximately, let me actually get rid of this. And I'll say that theta is equal to this, and I'll move this up here. So let me key that into the calculator, and let me make a better theta there. You can probably redo that. Well, if I punch that in, I get about 53 degrees. So 12.53 degrees. So I'm looking for this guy right there. So theta is about or approximately 12.53 degrees. All right, let's take a look at question 5. So here we want to find the distance between the point and the line. So here's your line. This is 3x plus 8y is equal to 5. And this is your point. Let me put a little border here. This is 7 comma negative 4. I'm going to go ahead and label this as x sub 1 and then y sub 1 so that we can plug into the formula. Now, this is the key thing here. And if you messed up on this problem, it's probably because you didn't write this in the correct form. Usually we work with standard form. We say it's ax plus by equals c. But for this formula, it has to be in what most people call general form. So that's ax plus by plus c equals 0. Okay, so what you'd actually have to do is subtract 5 away from each side. And so you'd have 3x plus 8y minus 5 is equal to 0. So if you made a mistake on this problem, it's probably because of this. A lot of people get confused by that. So let me actually move this up here. And I think we're going to have to go to a new sheet. I can't fit this on here. So we'll just come down here and paste this in. And we're going to work with our formula. Remember, the distance between this line and this point is given as, we have the absolute value of ax sub 1 plus by sub 1 plus c over the square root of a squared plus b squared. It's basically just a plug and chug formula. We've talked about where the formula comes from, and we've seen how to do this the long way in both the lesson and the practice test. But I mean, at this point, you can just plug in. It's not that big of a deal. We're just solving a basic problem. So you're going to label the coefficient for x as a, the coefficient for y as b, and this constant here is c. You can go plus negative if you need to. So basically, a is 3. So I'm going to plug that in here and then also here. And then b is going to be 8, so I'm going to plug that in here and then also here. And then c is going to be negative 5, so you can write minus 5 if you want, or you can go plus negative 5, whatever you want to do. Now, the other guy here is coming from this point. So for x sub 1, it's going to be 7. So we're going to plug that in there. And then for y sub 1, it's negative 4. So let's plug that in there. Okay, let me slide down here so we have a lot of room to work. I'm going to start up here and say that this is the absolute value of 3 times 7 is 21, plus 8 times negative 4 is negative 32. Let me go minus 32, and then we have minus 5. Let me actually change this to plus a negative and plus a negative, and I'll say negative 32 plus negative 5. That is going to give me negative 37. So let me just write minus 37 here. So 21 minus 37, that's going to be negative 16. And then when we take the absolute value, you're going to get positive 16. So you get 16 over, again, this is the square root of this 3 squared here is 9, 8 squared is 64, so 64 plus 9 is going to be 73, so this is the square root of 73. So you multiply this by the square root of 73 over the square root of 73, and so this equals 16 times the square root of 73 over 73. Okay, let me grab this, and let's paste this in, and this is what we want. So the distance between the point and the line is going to be 16 times the square root of 73 over 73.